Hello and welcome to Pre-Algebra Practice Set number 1. And in this video, we're going to look at some additional practice problems for our lesson on place value. So for the problems we're going to look at today, we want to state the place value for the underlying digit in each number. Let's look at our first problem. And we're going to start out with 5,089, and our underlying digit is this 0 here. So the easiest way to do this is to take this number and put it in our place value chart, and then we'll find the place value for the 0. So to use a place value chart, basically you take the rightmost digit of the number, which in this case is this 9 here, and you put it in the rightmost column of the place value chart. So the 9 goes into the ones place. Then as you move left in the number, you match that movement on the place value chart. So we move left one digit to 8, and then we move left one column to the tens. And we keep doing that. So the 0 goes in the hundreds, and then the 5 goes into the thousands. Now, we want to find the place value for the 0. The 0 is right here, so that's in the hundreds place. So the answer for this problem is that the 0 is in the hundreds place. Okay, for the next problem, we have 593,272. And again, we're looking for the place value for the underlying digit, and in this case, it's that 9 right there. So let's go ahead and take this number and put it into our place value chart. We start with the rightmost digit, which is this 2. We put it in the rightmost column, or the rightmost place of the place value chart, so the 2 goes into the ones place. And then we're moving left in the number, and we're matching that on the place value chart. So we have a 7 that's going in the tens place. We have a 2 that's going in the hundreds place. We have a 3 that's going in the thousands place. We have a 9 that's going in the 10,000s place. And then lastly, we have a 5 that's going in the 100,000s place. Now, the problem is asking us for the place value for the 9. So the 9 is right here, and that's in the 10,000s place. Okay, let's write that out. The 9 is in the 10,000s place. Okay, for the next one, we have 627,575,111. Again, we're looking for the place value for the underlying digit, which in this case is this 6 here. So let's go ahead and take our number and put it into the place value chart. So we start with the rightmost digit, which is this 1. We put it in the rightmost column, which is the ones. And then we just move left and we match that on the place value chart. So we're going to have a 1 that goes in the tens. And then we're also going to have a 1 that goes in the hundreds. Then we're going to have a 5 that goes in the thousands. We're going to have a 7 that goes in the 10,000s. We're going to have a 5 that goes in the 100,000s. We're going to have a 7 that goes into the millions. We're going to have a 2 that goes in the 10 millions. And then lastly, we're going to have a 6 that goes in the 100 millions place. Now, it's asking us for the place value of the 6. And as I just said, this 6 is in the 100 millions place. So let's go ahead and write that out. This is in the 100, okay, the 100 millions place. Okay, for this one we have 2,257,968, and we have this 8 that's underlined here. So this one's pretty easy. At this point, you probably know that the rightmost digit of a number is in the ones place. But we're going to go ahead and take this number and put it into the place value chart anyway, just to get some practice. So the rightmost digit, or the 8, goes into the rightmost column of the place value chart. So the 8 goes into the ones, and then we're just moving left. So the 6 goes into the tens, the 9 goes into the hundreds, the 7 goes into the thousands, the 5 goes into the 10,000s, this 2 goes into the 100,000s, and then this 2 goes into the millions. So we're looking for the place value of the 8, and that's real easy. It's in the rightmost column, or the ones place. So we'll put that this is in the ones place. Okay, for the next number, we have 6,751,031,927,151. So again, we want to find the place value for the underlying digit. And in this case, it's this 6 that's all the way to the left. Now, we'll take this number and we'll put it into the place value chart. Start with the rightmost digit, which is this 1. Put it in the rightmost column. So the 1 goes into the ones place. And we just move left in the number and we match that on the place value chart. So the 5 goes in the tens, the 1 here goes in the hundreds, the 7 here goes in the thousands, the 2 goes in the 10,000s, the 9 goes in the 100,000s, the 1 goes in the millions, the 3 goes in the 10 millions, the 0 goes in the 100 millions, this 1 goes in the billions, the 5 goes in the 10 billions, the 7 goes in the 100 billions, and then finally the 6 goes in the trillions. Now again, we're looking for the place value of the 6, and we just said that that's in the trillions place. So let's write that out. This is in the trillions place. Okay, so for the last couple of examples, we're not going to use a place value chart. So again, we want to state the place value for the underlying digit in each number. So we start out with 10,259,113. And we have two underlying digits. We have this 5 and this 0. So how are we going to do this without a place value chart? Well, if you watched the lesson, I kind of gave you a little trick for this. When you think about place value, pretty much anybody can remember that the rightmost digit of a number is in the ones place. So this is in the ones place. As you move to the left, okay, you multiply by 10. So going from this place to this place, I take 1, I multiply by 10, and I get 10. So the next place to the left is in the tens place. And I just keep doing that. 10 times 10 is 100. So the next place is the hundreds place. 100 times 10 is 1,000. So the next place over is the thousands place. Then I multiply 1,000 by 10, I get 10,000. So this is in the 10,000s place. Then 10,000 times 10 is 100,000. So this is in the 100,000s place. And then 100,000 times 10 is 1 million. So this is in the millions place. And then lastly, we multiply 1 million times 10 and we get 10 million. So this is in the 10 millions place. Okay. Now we're interested in the place value of the 5, which is in the 10,000s place. So the 5 is in the 10,000s place. And we're also interested in the place value of that 0 there, which is in the millions place. It's in the millions place. Okay, our last problem is 800,542,947. And we have 3 digits that are underlined here. We have this 4, we have this 5, and we have this 8. So again, we don't have a place value chart, but we're going to use our little trick. We're going to start at the rightmost digit of the number, which in this case is the 7, and we know that's in the ones. Now, as we move left, we multiply by 10. So 1 times 10 is 10. So the next digit is in the tens place. And then the next digit over is in the hundreds. And then this will be the thousands. Right? Just keep multiplying by 10. And then 1,000 times 10 is what? It's 10,000. So this will be the 10,000s place. And then this will be the 100,000s. This will be the millions. This will be the 10 millions. And then lastly, this will be the 100 millions. So again, the digits we're looking for the place value of the 4. And that's in the tens place. That's in the tens place. Then we're looking for the place value of this 5. And that is in the 100,000s place. So 100,000s place. And then lastly, we want the place value of the 8 there. And that is going to be in the 100 millions place. Okay, the 100 millions place. Hello and welcome to Pre-Algebra Test Section 1. And again, we're going to be looking at some problems that relate to our lesson on place value. So for the problems we're going to do today, we want to state the place value for the underlying digit in each number. So we're going to start out with part A. And for part A, we have the number 373. And we have the 7 here, the middle number that is underlined. So the way we're going to do this is we're going to take this number and we're going to put it in the place value chart. And to do that, we take the rightmost digit of the number, which is a 3, and we put it in the rightmost place or the rightmost column of the place value chart. So you'll have a 3 that goes into the ones place. And then we just move to the left in the number and we match that on the place value chart. So we take a 7 and we put it in the tens. Then lastly, we take this 3 and we put it in the hundreds. So it's asking for the place value of the 7, the middle number. And we can just look here on our chart and we can see that that's in the tens place. Okay, so the 7 is in the tens place. So for the next problem, it's part B. We're looking at 1094. And in this case, we have this 1 that is underlined. Now, again, we can feed this into the place value chart. We start with the rightmost digit of the number, which is a 4. We put in the rightmost column or the rightmost place of the place value chart. So the 4 goes into the ones place. Now we move to the left. We take the 9 and we put it in the tens place. We take the 0 and we put it in the hundreds place. And lastly, we take the 1 and we put it in the thousands place. Now we're looking for the place value of the 1. And again, as I just said, that's in the thousands place. So let's write that out. This is in the thousands place. Okay, for the final problem, we have 145,724. So again, let me erase this. We're looking for the place value of the underlined digit, which in this case is the 4. Most of you will know right off the bat that the rightmost digit is the ones, but we're going to feed it into this place value chart just to get some practice. So we'll take the rightmost digit of the 4, put it in the ones place. Then we'll move left. We'll take the 2 and we'll put it in the tens. We'll take the 7 and we'll put it in the hundreds. We'll take the 5 and put it in the thousands. We'll take the 4 and put it in the 10,000s. And lastly, we'll take this 1 and we'll put in the hundred thousands place. So again, the question that's asked of us is to find the place value of the 4, and that's in the ones place. So let's just go ahead and write that. So the 4 is in the ones place. Hello and welcome to Pre-Algebra Test Section 2. And again, we're going to be looking at some additional problems that deal with our lesson on place value. So for the problems today, we want to state the place value for the underlined digit in each number. So we're going to begin with part A, 595,039, where the 9 here is the underlined digit. Well, one way to deal with a problem like this is to use a place value chart. So we have one here. What we do is we just take the number and we fill the place value chart in. So you start with the rightmost digit of the number, which in this case is a 9, and we put it in the rightmost column or the rightmost place of the place value chart. So the 9 would just go in the ones place. Now you move left in the number and you match that movement on the place value chart. So you go 1 digit to the left, which is a 3, and you put that 1 place to the left on the place value chart. So the 3 is in the tens place. Then you keep going. The 0 will go in the hundreds place. The 5 will go in the thousands place. The 9 will go in the 10,000s place. And then lastly, the 5 will be in the 100,000s place. Now, the problem asks us for the place value of the underlined digit, which is the 9. So that's this 9 here, and that's in the ones place. So this is in the ones place. Okay, for part B, our second problem, we have 7,335,197, and now our underlined digit is this 3 here. You have to be careful because you have 2 3s side by side. Just know that's the leftmost 3. So we're going to use our place value chart again. Take your rightmost digit, or this 7, put it in the rightmost column, which is the ones column or the ones place. Then we're going to move left. So we're going to take the 9 and we're going to put it in the tens place. We're going to take the 1 and put it in the hundreds place. We're going to take the 5 and put it in the thousands place. We're going to take the 3 and put it in the 10,000s place. We're going to put the other 3, the 3 we're looking for, and put it in the 100,000s place. And then lastly, we're going to take the 7 and put it in the millions place. Now, as I just mentioned, we want this 3 right here. It's the leftmost 3, this one right here. So it's in the 100,000s place. Okay, let's write that out. This 3 is in the 100,000s place. Okay, for part C, our final problem, we have 153,215,613. And in this case, we're looking for this 5 here. That's our digit that's underlined. So again, we're just going to fill in the place value chart. So we'll start with the rightmost digit, or the 3. Put that in the rightmost column, what we know of as the ones place. Now we're going to move to the left. We'll take the 1 and put it in the tens place. We'll take the 6 and put it in the hundreds place. We'll take the 5 and put it in the thousands place. We'll take the 1 and put it in the 10,000s place. We'll take the 2 and put it in the 100,000s place. We'll take the 3 and put it in the millions place. We'll take the 5 and put it in the 10 millions place. And lastly, we'll take this 1 and put it in the 100 millions place. So we were looking for the place value again for this 5, and that is here. That's in the 10 millions place. Okay, so let's write that out. The 5 is in the 10 millions place. Hello and welcome to Pre-Algebra Test Section 3. And again, here we're going to look at some additional practice problems for the lesson on place value. So for the practice problems we look at today, we want to state the place value for the underlying digit in each number. So let's start out with part A here, where we have 793,227,521. So the underlying digit here is this 9. So we want to find the place value for that 9. And the way we're going to do it on this particular problem is we're going to use a place value chart. So to use it, we just take the number and we feed it into the place value chart. We start with the rightmost digit, which in this case is a 1, and we put it in the rightmost column. So we put it in the ones column, or you could say the ones place. Now as we move left in the number, we're going to match that movement in the place value chart. So we'll go to the 2, and so we'll put that in the next column to the left. So that's the tens column or the tens place. And then we just keep moving left. So we'll take the 5 and put it in the hundreds place. We'll take the 7 and put it in the thousands place. We'll take the 2 and put it in the 10,000s place. We'll take this 2 and put it in the 100,000s place. We'll take the 3 and put it in the millions place. We'll take the 9 and put it in the 10 millions place. And then lastly, we'll take the 7 and put it in the 100 millions place. Now, we're looking for the place value of this 9. And from the place value chart, we can see that the 9 is in the 10 millions place. Let's go ahead and write that out. The 9 is in the 10 millions place. Okay, for part B, we have 103,799, and our underlying digit here is a 7. Now you'll notice here that I don't have a place value chart, and that's because we want to practice getting place values without a place value chart. And the way that you do this is you use a little trick. Let's rewrite the number, 103,799. Now at this point, probably all of you know that the rightmost digit of a number is in the ones place. Now, as you move to the left, so as I move one place to the left, I simply multiply by 10. So if I started out in the ones, I can think of that as just 1. 1 times 10 is 10. So the next place to the left is the tens. And I keep doing that. As I move to the left, I multiply by 10. So 10 times 10 is 100. So the next place is the hundreds. And 100 times 10 is 1,000. So the next place is the thousands. 1,000 times 10 is 10,000. So the next place is the 10,000s. And then 10,000 times 10 is 100,000. So this 1, our final digit to the left, is in the 100,000s place. Okay, pretty simple stuff. Now we're looking for the place value of the 7. That's right here, and that's in the hundreds place. Okay, so our 7 is in the hundreds. Let me just arrow down. That's in the hundreds place. Okay, so for part C, we have 2,375,118, and the 7 here is underlined. And we don't have a place value chart, so again, we're going to use the same technique. And I'm just going to do it on the number that's already given. I'm not going to rewrite it. So the rightmost digit is in the ones place. And then as we move left, remember, we just multiply by 10. So 1 times 10 is 10. So the next place to the left is in the tens. 10 times 10 is 100. So this is the hundreds. 100 times 10 is 1,000. So this is the thousands. 1,000 times 10 is 10,000. So this is the 10,000s. 10,000 times 10 is 100,000. So this is the 100,000s. And then lastly, 100,000 times 10 is a million. So this is the millions. Okay. Now we're looking for the place value for the underlying digit, and that's the 7. And that is in the 10,000s place. So this is in the 10,000s place. Hello and welcome to Pre-Algebra Test Section 4. And again, in this video, we're going to look at some additional problems that deal with place value. So for the problems today, we want to state the place value for the underlying digit in each number. So for part A, our first problem, we have 6,331,227,513,214. And we're looking for the place value of this 3 here. That's what's underlined. And we're going to use our place value chart to find it. Now, to use the place value chart, we start at the rightmost digit, which in this case is a 4, and we put it in the rightmost column. Okay, so that's going to go in the ones column or the ones place. So the 4 goes here. And then we're just moving to the left in the number, and we're matching that movement on the place value chart. So the 1 goes here, the 2 goes here, and then so on and so forth. So we'll have a 3 here, a 1 here, a 5 here. We'll have a 7 here, a 2 here, a 2 here. And then we'll have a 1 here, a 3 here, a 3 here, and then finally a 6. So we're looking for the place value for this 3 here. So notice you have 2 3s side by side. You have a 3 and a 3. We want the right 3. So we want this one right here. And that's in the 10 billions place. So let's write that out. This 3 is in the 10 billions place. Okay, for part B, we have 877,531,000. And you'll notice that we don't have a place value chart here. So to find the place value of the underlying digit, this 7, we're going to use a little technique. Now, when you think about place values, essentially the first position or the rightmost position of a number is in the ones place. So just think of the number 1. As you move to the left 1 digit, you just multiply by 10. So 1 times 10 is 10. So the next place is the tens place. Now we keep doing that. 10 times 10 is 100. So the next position to the left is in the hundreds place. This continues. 100 times 10 is 1,000. So this is the thousands place. 1,000 times 10 is 10,000. So this is the 10,000s place. And then I'm just going to keep going. So 10,000 times 10 is 100,000. So this is the 100,000s place. And then this will be the millions place. This will be the 10 millions place. 10 millions place. And then lastly, this 8 will be in the 100 millions place. So now we know that the 7, which is our underlying digit, and it's the rightmost 7, is in the millions place. Okay, it's in the millions place. Let's just write that out. This 7 is in the millions place. Hello and welcome to Pre-Algebra Test Section 5. And again, we're going to be looking at some practice problems that deal with place value. So we want to state the place value for the underlying digit in each number. And let's scroll down and go to the first problem, which will be part A. We have 17,395,221,422. Now we don't have a place value chart, which is something we've used, but when you don't have one, you can kind of just use our little trick that we've been talking about in the lesson and our previous practice problems. Essentially, the rightmost digit of a number is in the ones place. So it's in the ones place. As you move a digit to the left, you're just multiplying the previous place by 10. So in other words, think about the ones place just with the number 1. If I multiply 1 times 10, I get 10. So the next place to the left is the tens place. Then just think about 10 times 10 will give me 100. So the next place to the left is the hundreds place. We just keep doing this. 100 times 10 is 1,000. So this is the thousands place. Then we get the 10,000s place. Then we get the 100,000s place. And then we get the millions place. The 10 millions place. The 100 millions place. This would be the billions place. And then finally we'd have the 10 billions place. Now, we want to find the place value for the underlying digit, which is this 2 right here. And that is in the hundred thousands place. So let's write that out. The 2 is in the hundred the hundred thousands place. Okay, for the final problem, part B, we have 8,1,343,879,424. So again, we're going to use our technique. Let's start at the rightmost digit, and this 4 here is in the ones. And as we move left, we're multiplying by 10. 1 times 10 is 10. So then we get the tens, then we're going to get the hundreds, then we're going to get the thousands, then we're going to get the 10,000s, then we're going to get the 100,000s. And again, keep multiplying by 10, so this will be the millions, then the 10 millions, then the 100 millions. And this will be the billions. This will be the 10 billions. And this will be the 100 billions. And then lastly, we'll have the trillions. Okay, so the place value for this 8 here is going to be the trillions place. So the 8 is in the trillions place. Hello and welcome to Pre-Algebra Practice Set number 2. And in this video, we're going to be looking at some additional practice problems for our lesson on expanded notation. So we'll start out with our first problem, and we want to write 735 in expanded notation. So 735. Just to kind of think about the place value for each digit here, the 5 is in the ones place, the 3 is in the tens place, and the 7 is in the hundreds place. So to write a number in expanded notation, we simply form the sum of each digit multiplied by its corresponding place value. So in other words, we'd start with the 7, the leftmost digit, and it's in the hundreds place. So the digit is a 7, and we multiply it by its corresponding place value. Again, it's in the hundreds place, so we'd have 7 times 100. Then plus, the 3 here is in the tens place. So the digit is a 3, and we're multiplying it by 10. Then plus, we have a 5 in the ones place, so 5 times 1. Okay, do a little multiplication here. 7 times 100 is 700. Plus 3 times 10, that's 30. And plus 5 times 1, that's 5. So as I told you in the lesson, expanded notation is just showing you the value of each digit in a number. This 7 here, because it's in the hundreds place, has a value of 700. Then this 3 here, because it's in the tens place, has a value of 30. And then the 5, because it's in the ones place, is still just a 5, right? 5 times 1 is just 5. So there's your number 735 written in expanded notation. It's 700 plus 30 plus 5. Okay, for the next problem, we want to write 20,761 in expanded notation. So 20,761, and let me just kind of label this. The 1 is in the ones place. The 6 is in the tens place. The 7 is in the hundreds place. The 0 is in the thousands place. And the 2 is in the 10,000s place. So to write this number in expanded notation, I'm going to start at the leftmost number, that 2. And I'm going to multiply it by its corresponding place value. So 2 times, it's in the 10,000s place, so 2 times 10,000. Then plus. Just move it to the right. I have a 0 in the thousands place. So the 0 is just a placeholder. So I can just skip that. I don't need to write it in. But just for this example, I'm just going to put 0 times, it's in the thousands place, so times 1,000. Okay, then plus, next we have a 7 in the hundreds place. So that's 7 times 100. Then plus, we have a 6 in the tens place, so 6 times 10. Then finally, plus 1 times 1, right? Because we have a 1 in the ones place. So do a little multiplication. 2 times 10,000 is 20,000. So 20,000. Plus 0 times 1,000 is 0. And as we'll go over in a future lesson, 0 times any number is always 0. So I could put 0 in here, but it's not necessary because adding 0 to a number doesn't change its value. So I'm just going to move on to this 7 times 100 here. So 7 times 100 is 700. And plus 6 times 10, that's 60. And plus 1 times 1, that's 1. So again, expanded notation has allowed us to see that this 2 is 20,000. This 7 is 700. This 6 is 60. And this 1 is just 1. And again, this 0 here, don't be confused by the 0 there. We have a 0 in the thousands place as a placeholder. Just think about the fact that if you have 20,761 and you didn't have something like 0 that could stand for saying, hey, I don't have anything in this place, but to the next place to the left I have a 2. Well, if I don't have anything there and I don't have anything like a placeholder, the number would collapse down and you would have something like 2,761, and you wouldn't be able to tell the difference between those two numbers. So that's why we have 0 in our number system, and I keep kind of mentioning that in every video so that hopefully you understand that. That 0 is very important because it's holding a space. Okay, it's holding a space so that that 2 can be in its proper position, which is in the 10,000s place, telling us we have 20,000 there. Okay, now we want to write 353,275 in expanded notation. So 353,275. So the 5's in the 1's place, the 7's in the 10's place, the 2 is in the 100's place, the 3 is in the thousands place, the 5 is in the 10,000's place, and the 3 is in the 100,000's place. And to save time, I'm just going to do the multiplication as I go. So I start at the leftmost digit, which is the 3, and I'm going to multiply it by its corresponding place value. So it's in the 100,000s place. 3 times 100,000 is 300,000. So 300,000. And plus, now I have a 5 in the 10,000s place. 5 times 10,000 is 50,000. And plus, I have a 3 in the thousands place. 3 times 1,000 is 3,000. And plus, I have a 2 in the hundreds place. 2 times 100 is 200. And plus, I have a 7 in the tens place. 7 times 10 is 70. And finally, 5 times 1 is just 5. So again, writing this number in expanded notation allows me to see the value of each digit. So this 3 has a value of 300,000. This 5 has a value of 50,000. This 3 has a value of 3,000. This 2 has a value of 200. This 7 has a value of 70. And then this 5 is still just a 5. Okay, for the last one, we want to write 703,271,050,146 in expanded notation. So lucky for us, this number has a lot of zeros. Otherwise, it would take a long time to write it in expanded notation. Now, I'm just going to rewrite this number here. 703,271,050,146. So we're going to start by multiplying the leftmost digit, which is that 7, by its corresponding place value. So it's in the 100 trillions place. 7 times 100 trillion is 700 trillion. So 700 trillion. Then plus. So next I have a 0 in the 10 trillions place. And I can skip that over because we're writing this in expanded notation. So I just move on to the 3 that is in the trillions place. So 3 times a trillion is 3 trillion. So 3 trillion. Then plus. I have a 2 in the 100 billions place. So that's 2 times 100 billion or 200 billion. 200 billion. And plus, I have a 7 in the 10 billions place. 7 times 10 billion is 70 billion. And plus, I have a 1 in the billions place. 1 times a billion is a billion. Then plus, I have a 0 in the 100 millions place, so I don't need to include that. Then I have a 5 in the 10 millions place. 5 times 10 million is 50 million. So 50 million. And then we kind of get a break because we have a 0 in the millions place. We have a 0 in the 100,000s place. We have a 0 in the 10 thousandths place, and a 0 in the thousandths place. So we can kind of skip over all those and just go to the 1 in the hundredths place. 1 times 100 is 100. Plus, we have a 4 in the tens place. 4 times 10 is 40. And then lastly, plus, we have a 6 in the ones place. 6 times 1 is 6. So 703,271,050,146, written in expanded notation, is 700 trillion. And that comes from this 7 here in the 100 trillions place. 7 times 100 trillion is 700 trillion. Plus 3 trillion. 3 trillion. That comes from this 3 here in the trillions place. 3 times a trillion is 3 trillion. Plus 200 billion. That comes from this 2 here in the 100 billions place. So 2 times 100 billion is 200 billion. Then plus 70 billion. That comes from this 7 here in the 10 billions place. 7 times 10 billion is 70 billion. Then plus we have 1 billion. That comes from a 1 in the billions place. 1 times a billion is a billion. Then plus 50 million. That comes from the 5 in the 10 millions place. 5 times 10 million is 50 million. Then we have plus 100. That comes from the 1 in the hundreds place. 1 times 100 is 100. Then plus 40. That comes from the 4 in the tens place. 4 times 10 is 40. Then finally plus 6. That comes from the 6 in the ones place. 6 times 1 is 6. Hello and welcome to Pre-Algebra Test Section 1 on expanded notation. So our problem is to write 75,274 in expanded notation. So let me just kind of label this number real quick. So the 4 is in the ones place. The 7 is in the tens place. The 2 is in the hundreds place. The 5 is in the thousands place. And finally the 7 is in the 10,000s place. So as I taught you in the lesson, to write a number in expanded notation, you form the sum of each digit multiplied by its corresponding place value. So I would start with the leftmost digit, which is this 7 here. So 75,274 is equal to this 7, that's our digit, multiplied by its corresponding place value. So it's in the 10,000s place, so times 10,000. Then plus. Next we have a 5 in the thousands place, so we would have 5 times 1,000. Then plus. Now we have a 2 in the hundreds place, so 2 times 100. Then plus. We have a 7 in the tens place, so 7 times 10. And finally plus 4 times 1, right? We have a 4 in the ones place. Let's kind of clean this up. 7 times 10,000 is 70,000. Plus 5 times 1,000, that's 5,000. Plus 2 times 100, that's 200. Plus 7 times 10, that's 70. And then finally, plus 4 times 1, that's 4. So 75,274, written in expanded notation, is 70,000 plus 5,000 plus 200 plus 70 plus 4. And again, to kind of think about what this means, we're saying that the value of this digit 7 is 70,000. The value of this digit 5 is 5,000. The value of this digit 2 is 200. The value of this digit 7 is 70. And the value of the digit 4 is 4. Hello and welcome to Pre-Algebra Test Section 2 on expanded notation. So for this problem, we want to write 393,714 in expanded notation. So let me start by just labeling the digits of the number in terms of their place values. So the 4 is in the ones place, the 1 is in the tens place, the 7 is in the hundreds place, the 3 is in the thousands place, the 9 is in the 10,000s place, and then this 3 is in the 100,000s place. So I'm going to write this number, 393,714 is equal to, we're going to write the number in expanded notation. And to do that, we form the sum of each digit multiplied by its corresponding place value. So I'm going to start with the leftmost digit, which is this 3 here, and it's in the 100,000s place. So I would have 3 times 100,000. So 3 times 100,000 is 300,000. So I'm going to write 300,000 here. Then plus, next I have a 9 that is in the 10,000s place. So 9 times 10,000 is 90,000. Then plus, I have a 3 in the thousands place. 3 times 1,000 is 3,000. Then plus, I have a 7 in the hundreds place. 7 times 100 is 700. Then plus, I have a 1 in the tens place. 1 times 10 is 10. And finally, plus 4 in the ones place. 4 times 1 is 4. So 393,714 written in expanded notation is 300,000 plus 90,000 plus 3,000 plus 700 plus 10 plus 4. And again, what we're doing here is we're emphasizing place value. So this 3 here has a value of 300,000. This 9 has a value of 90,000. This 3 has a value of 3,000. This 7 has a value of 700. This 1 has a value of 10. And this 4 has a value of just 4. Hello and welcome to Pre-Algebra Test Section 3 on expanded notation. So our problem is to write 65,301,052 in expanded notation. So let's start by just rewriting the number 65,301,052. Now, to write a number in expanded notation, I form the sum of each digit multiplied by its corresponding place value. So starting at the leftmost digit in this number, the 6 is in the 10 millions place. So if I multiply 6 times 10 million, I would get 60 million. So 60 million. Then if I move to the right, this 5 is in the millions place. 5 times 1 million is 5 million. So plus 5 million. Plus, now I have a 3 in the 100,000s place. 3 times 100,000 is 300,000. And plus, I have a 0 here, so I can just skip that over. I have a 1 in the thousands place. 1 times 1,000 is 1,000. And plus, I have a 0 here, so I can skip that over. Then I have a 5 that's in the tens place. 5 times 10 is 50. And plus, finally I have a 2 in the ones place. 2 times 1 is 2. So my number, 65,301,052, written in expanded notation is 60 million plus 5 million plus 300,000 plus 1,000 plus 50 plus 2. And again, to kind of go through this, the 6 here is 60 million. The 5 here is 5 million. The 3 here is 300,000. The 1 is 1,000. The 5 is 50. And then the 2 is just a 2. Hello and welcome to Pre-Algebra Test Section 4 on expanded notation. So we want to write 71,005,391,204 in expanded notation. Let's start by rewriting this number. 71,005,391,204. So to write a number in expanded notation, we form the sum of each digit multiplied by its corresponding place value. So starting at the leftmost digit, this 7, we just multiply it by its corresponding place value. So the 7 is in the 10 billions place. So 7 times 10 billion is 70 billion. So let's write that. Okay, plus. Next, we have a 1 that's in the billions place. So 1 times 1 billion is 1 billion. Plus, we have a 0 here and a 0 here. So we can skip those when we're writing a number in expanded notation. Then we have a 5. Okay, the 5 is in the millions place. So 5 times 1 million is 5 million. And plus, next we have a 3 in the 100,000s place. 3 times 100,000 is 300,000. And plus, we have a 9 in the 10,000s place. 9 times 10,000 is 90,000. And plus, next we have a 1 in the thousands place. 1 times 1,000 is 1,000. And plus, next we have a 2 in the hundreds place. 2 times 100 is 200. We have a 0, so we can skip over that. Then we have a 4 in the ones place, so plus 4 times 1 or 4. So the number 71,005,391,204 written in expanded notation is 70 billion plus 1 billion plus 5 million plus 300,000 plus 90,000 plus 1,000 plus 200 plus 4. Hello and welcome to Pre-Algebra Test Section 5 on Expanded Notation. So our problem is to write 396,211,595,213 in expanded notation. So let's go ahead and write this number again. 396,211,595,213. Okay, so to write a number in expanded notation, we form the sum of each digit multiplied by its corresponding place value. So we're going to start at the leftmost digit, and that 3 is in the 100 billions place. So we would multiply 3 times 100 billion. That would give us 300 billion. So 300 billion. Then plus. We move to the next digit to the right. We have a 9 in the 10 billions place. 9 times 10 billion is 90 billion. So 90 billion. Then plus. Next we have a 6 in the billions place. So 6 times a billion would be 6 billion. And plus. We have a 2 in the 100 millions place. So 2 times 100 million is 200 million. And plus, we have a 1 in the 10 millions place. So 1 times 10 million is 10 million. And plus, we have a 1 in the millions place. 1 times a million is a million. Then plus, we have a 5 in the 100,000s place. 5 times 100,000 is 500,000. And plus, we have a 9 in the 10,000s place. 9 times 10,000 is 90,000. And plus, we have a 5 in the thousands place. 5 times 1,000 is 5,000. And plus, we have a 2 in the hundreds place. 2 times 100 is 200. And plus, we have a 1 in the tens place. 1 times 10 is 10. Then plus, finally, we have a 3 in the ones place. 3 times 1 is 3. So 396,211,595,213 written in expanded notation is 300 billion plus 90 billion plus 6 billion plus 200 million plus 10 million plus 1 million plus 500,000 plus 90,000 plus 5,000 plus 200 plus 10 plus 3. Hello, and welcome to Pre-Algebra Practice Set 3. In this video, we're going to look at some additional practice problems for the lesson that we did on inequalities and the number line. So for the problems we're going to look at today, we want to replace each question mark with the inequality symbol less than or greater than. So before I start, I just want you to remember from the lesson that the symbol is always going to point to the smaller number. So let's look at our first problem. We have 7 question mark 1. So let's take a look at the number line and see that 7 is here and 1 is here. Now in the lesson I told you that numbers increase moving from left to right. So if a number is to the right of another number, that means it's a larger number. So since 7 lies to the right of 1 on the number line, 7 is a larger number. So if we have 7 question mark 1, we want to point the symbol to the smaller number. This is the smaller number, so we're going to have a greater than symbol, right? A greater than symbol. So it'll be 7 is greater than 1. Again, we're pointing the symbol to the smaller number. Now, if we would have had the reverse, if we would have had 1 on the left and 7 on the right, we'd use a less than. We'd use a less than because the 1 is on the left now, and we point the symbol to the smaller number. Here we have 2 question mark 9. So on my number line, I see that 2 is here and 9 is here. 9 is to the right of 2, so 9 is the larger number. So if we want to point the symbol towards the smaller number, we want to point it towards 2. So that means we're going to use a less than, right? 2 is less than 9. Again, we're pointing the symbol towards the smaller number. And again, if the numbers were reversed to where 9 was on the left and 2 was on the right, then we'd be looking at using a greater than. Again, you're always using the symbol that points towards the smaller number. So in this case, we use the greater than because the symbol would then point to the 2. Okay, now we have 6 question mark 3. And looking at the number line, we have 6 here and we have 3 here. So everybody knows automatically that 6 is a larger number than 3. You have $6, you have more obviously than if you have $3. But again, just proving this point on the number line, 6 is larger than 3 because 6 lies to the right of 3 on the number line. And so when we look at these two numbers, we're going to put a greater than symbol in here because we want the symbol to point to the smaller number, and the smaller number is 3. Okay, here we have 1 question mark 0. So on the number line, we have 1 here and 0 here. So 1 is the larger number because 1 is to the right of 0 on the number line. So we have 1 and 0. And so where are we going to put our symbol? We want to point it to the smaller number. So we're going to point it to the 0. So that means we're going to use a greater than. Okay, we're going to use a greater than. 1 is greater than 0. Okay, we have 5 question mark 6. So here's 5 on the number line and here's 6. And so 6 is the larger number, again, because it lies to the right of 5 on the number line. So 5 and 6 here. We want the symbol to point to the smaller number. So we want the symbol to point towards the 5. So we're going to use a less than. Okay, again, we're pointing the symbol towards the smaller number. So 5 is less than 6. For our final problem, we have 2 question mark 4. So here's 4 on the number line and here's 2. So obviously 4 is greater than 2 because 4 lies to the right of 2 on the number line. And so again, we want the symbol to point to the smaller number. So we're going to point the symbol towards the 2. That means we're going to use a less than. 2 is less than 4. Hello and welcome to Pre-Algebra Test Section 1 on inequalities and the number line. So for the problems we're going to look at today, we want to replace each question mark with the inequality symbol less than or greater than. So for the first problem, we have 3 question mark 7. So if we look at our number line, we can see 3 is here and 7's here. Now, as I told you in the lesson, numbers increase moving from left to right. So 7 is a larger number than 3 because 7 lies to the right of 3 on the number line. Now, when we talk about putting in the correct inequality symbol between 3 and 7 there, we want a less than here. And the reason we want a less than is because we want the symbol that is going to point to the smaller number. You kind of think about this as it pointing to this 3 here, right? This is the open side and this is the pointy side. So the less than symbol is what we use here because it points to the 3 and the 3 is the smaller number. Here we have 12 question mark 5. So looking at the number line, I have 5 here, but my number line kind of stops putting notches at 9. I mean, it has an arrow here that says that, hey, this continues, but I don't see 12. What I do know is that 12 is to the right of 5 on the number line, so it's a larger number. So in this case, 12 and 5 here, we know 5 is going to be smaller, so we're going to point the symbol to the smaller number, and the smaller number again is 5. So we're going to use a greater than. 12 is greater than 5. Here we have 2 question mark 0. So we have 2 here and 0 here. 2 lies to the right of 0 on the number line. So we know that 2 is greater than 0. Again, we're going to point the symbol towards the smaller number. So we're using a greater than in this case. Here we have 1 question mark 8. So looking at the number line, we have 1 here, we have 8 here. So 8 is the larger number because it lies to the right of 1 on the number line. So we'll have 1 is less than 8, right? We're going to use the symbol that points to the smaller number. Again, the smaller number is 1, and this symbol is pointing towards the 1. Okay, for the final problem, we have 5 question mark 3. And looking at the number line, 5 is here and 3 is here. So 5 is the larger number because 5 lies to the right of 3 on the number line. So So when we think about the symbol we're going to use, we have 5 and 3. We want the symbol to point towards the 3 because it's smaller, so we're going to use a greater than, right? So 5 is greater than 3. Hello and welcome to Pre-Algebra Test Section 2 on inequalities and the number line. So for the problems we're looking at today, we want to replace each question mark with the inequality symbol less than or greater than. Okay, so we're going to start out with 12 question mark 1. So we don't see 12 as one of the notches on our number line. It kind of stops at 9, and then we have this arrow to indicate that it continues forever. But that's okay. We can see that 1 is here, and we know 12 is somewhere to the right of 1 on the number line, so we know 12 is bigger. So if we think about 12 and 1, what symbol would I put in here? Well, again, I have the choice of less than or greater than. I want the symbol that's going to point to the smaller number. So I want the symbol that's going to point to the 1, so it needs to point to the right. So I'm going to use this guy. I'm going to use the greater than symbol. So 12 is greater than 1. Again, we're using the one that points, so that little point right there, to the smaller number. What about 0 question mark 3? Well, here's 0 on the number line, and here's 3. And it's obvious that 3 is bigger because 3 lies to the right of 0 on the number line. So again, when we think about what inequality symbol to use, we want to point the inequality to the smaller number. So we're going to use a less than symbol. 0 is less than 3. See how it's pointing towards the 0. Okay, for the next one, we have 2 question mark 8. And looking at the number line, we can see the position of 2 is here, and the position of 8 is there. So 8 is clearly bigger, right? 8 lies to the right of 2 on the number line. And so when we think about which inequality symbol to use, remember we want to point the symbol towards the smaller number. So we're trying to point it towards the 2, and we're going to use the less than to do that. So 2 is less than 8. Now we have 6 question mark 4, and 6 is here on the number line, and 4 is here. So 6 is clearly bigger, right? Because 6 lies to the right of 4 on the number line. So we have 6 and we have 4. Again, use the symbol that points to the smaller number. So we're pointing towards the 4, so we're going to use the greater than symbol. So 6 is greater than 4. Okay, and so for our last problem, we have 4 question mark 1. So we have 4 here and 1 here. So 4 is bigger, again, because 4 lies to the right of 1 on the number line. So we're going to take 4 and 1 and think about which inequality symbol we're going to use there. Again, point the symbol towards the smaller number. The smaller number is 1, so we're going to use a greater than symbol. 4 is greater than 1. Hello and welcome to Pre-Algebra Test Section 3 on inequalities and the number line. So for the problems we're going to look at, we want to replace each question mark with the inequality symbol less than or greater than. So for the first problem, we have 2 question mark 11. And looking at our number line, we can see that 2 is here. We don't have a notch for 11, but we know it's somewhere over here. And what we were told in the lesson is that numbers increase moving from left to right. So since 11 is to the right of 2 on the number line, it's a larger number. So when we think about the relationship between 2 and 11, we want to put the inequality symbol that points towards 2, right? Because it's the smaller number. So our choices were to use the less than or the greater than. We're going to use the less than because it points towards the 2. So we would have 2 is less than 11. Okay, for this problem, we have 0 question mark 7. And looking at the number line, we see that 0 is here and 7 is here. So 7 is clearly the larger number because 7 lies to the right of 0 on the number line. And so when we think about 0 and 7, we're going to use a less than symbol here because we want the symbol that points to the smaller number. And in this case, the smaller number is 0. Okay, now we have 7 question mark 0. So we've reversed the position of the numbers from the last problem. So we have the same situation. We have 7 and we have 0. But again, we've reversed the position of the number. So in the first case, we had 0 is less than 7. But that's because the smaller number's on the left. In this case, the smaller number's on the right. We have 7 and we have 0. So again, we're using the symbol that points to the smaller number. So now we want to use the greater than symbol. 7 is greater than 0 because in each case, the symbol points to the 0, the smaller number. Here we have 8 question mark 9. And on the number line, we can see that 8 is here and 9 is here. So 9 lies to the right of 8 on the number line, so it's the larger number. So we have 8 and we have 9. And again, we want to use the symbol that points to the smaller number. So we're going to use the less than symbol because that's going to point towards the 8. So we have 8 is less than 9. Okay, for the final problem, we have 10 question mark 1. And we have 1 on the number line, but we don't have a notch for 10. It's somewhere over here. And we know that 10 is larger than 1. 10 would be, again, somewhere over here. It's to the right of 1 on the number line. And so when we write our problem again, 10 and 1, we know 1 is the smaller number, and we know we want the symbol that points to the 1, so we would use a greater than. Right? 10 is greater than 1. Hello, and welcome to Pre-Algebra Test Section 4 on inequalities and the number line. Okay, so for our problems today, we want to replace each question mark with the inequality symbol less than or greater than. So for the first problem, we have 6 question mark 12. So let's look at 6 on the number line. That's here. And we don't have a notch for 12, but we know it's over here. Now, what we learned in the lesson was that numbers increase from left to right. So if a number like 12 is to the right of another number like 6 on the number line, we know it's a larger number. So we have 6, and again, we have 12. Now, if we know 6 is the smaller number, we have a choice between using the less than symbol and the greater than symbol. Which one do we want to use? Well, again, as I taught you in the lesson, we want to point the symbol towards the smaller number. So we want to use this less than symbol because that's going to point towards the 6. So we would have 6 is less than 12. And another way you can check it is just read it. 6 is less than 12 and just say, okay, is that true? Well, yes, it is. If I had chose this other symbol and I had said 6 is greater than 12, just reading that, you know that's wrong. 6 is not greater than 12. It's a smaller value. So again, here's our answer. 6 is less than 12. Okay, here we have 3 question mark 1. So we have 3 here on the number line. We have 1 here. So 3 lies to the right of 1 on the number line, so it's the larger number. So we have 3 and we have 1. Again, we want to use the symbol that points to the smaller number. So in this case, we're going to use a greater than, right? Because the symbol is going to point towards the 1, and that is smaller. So we have 3 is greater than 1. Okay, here we have 0 question mark 9. So on the number line, we have the 0 here, and we have 9 here. Okay, so we can see that 9 is the larger number. 9 lies to the right of 0 on the number line. So when we look at the relationship between 0 and 9, which symbol do we want to put in between them? We want to use a less than, because we want to use a symbol that's going to point towards the smaller number, and the smaller number again is 0. So 0 is less than 9. Okay, for the next one we have 14 question mark 10. We're going to do this one without a number line. We all know that 14 is a bigger number than 10. If you had $14 in your pocket, you would have more money than if you just had $10 in your pocket. So if 14 is the larger number, which symbol do I want to use? Well, I want to use the greater than symbol, right? Because remember, I want to point the symbol towards the smaller number. And the greater than symbol does that. So 14 is greater than 10. Okay, for the last one, we have 12 question mark 4. And we should all know that 12 is a larger number than 4. And so if we look at 12 and we look at 4, which symbol are we going to use? We're going to, again, use a greater than symbol because the 4 is smaller, and we want the symbol that points towards the smaller number. So we would have 12 is greater than 4. Hello, and welcome to Pre-Algebra Test Section 5 on inequalities and the number line. So for the problems we're going to look at, we want to replace each question mark with the inequality symbol less than or greater than. So we're going to start out with 3 question mark 8. And if we look at the number line, we have 3 here and 8 here. And what I taught you in the lesson is that numbers increase moving from left to right. So 8 is to the right of 3 on the number line, so that tells us it's a larger number. So if we have 3 and we have 8, 3 is going to be the smaller number, 8 is going to be the larger number. Now, we want to put an inequality symbol between them that represents the relationship. The choices we had were the less than or the greater than. Now, what I told you in the lesson is you always want to use the symbol that points to the smaller number. So in this case, we're going to use this symbol, which is the less than symbol, because it's going to point to 3, the smaller number. So we would have 3 is less than 8. So now we have 13 question mark 11. We don't have a number line, but most of you will know that 13 is the larger number. So if we have 13 and we have 11, we want the symbol that points to the smaller number. And the smaller number is 11, so we're going to use a greater than in this case, because the greater than symbol will point to the 11. So we'd have 13 is greater than 11. Next we have 17 question mark 82. So 17 is the smaller number in this case. 82 is the larger number. So we want the symbol that's going to point towards the 17, and that's going to be the less than symbol. Right? We'd have 17 is less than 82. We have 100 question mark 150. 100 in this case is the smaller number. 150 is the larger number. So which symbol do we want to use? Well, we want to use the less than symbol because, again, we want the symbol that points to the smaller number. The smaller number is 100. So we would have 100 is less than 150. And for our last problem, we have 30,000 question mark 10,570. So 30,000 is the larger number. 10,570 is the smaller number. So we want to use the inequality symbol again that's going to point towards 10,570 because it's smaller. So if we do that, we're going to be using a greater than symbol. So we'd have 30,000 is greater than 10,570. Hello, and welcome to Pre-Algebra Practice Set number 4. And in this video, we're going to look at some additional problems for the lesson that we did on rounding whole numbers. Okay, for the first problem, we want to round 227 to the nearest 10 and the nearest 100. So let's start out with rounding it to the nearest 10. So we have our number 227. The very first step is to locate the digit in the round-off place. So if we're rounding to the nearest 10, we want the digit in the tens place. So that's going to be this 2 right here. Now, the next step is to locate the digit to the right of the round-off place. So that's this 7 right here. And then basically you're looking to see which category it falls into. You have 2. You have where the digit is 4 or less, and then you have where the digit is 5 or larger. The 7 is in the category of 5 or larger. And when this happens, you increase the digit in the round-off place by 1. So this 2 is a digit in the round-off place, so we're going to increase it by 1, so it will become a 3. So you will have this 2 right here will stay the same. Then, as I just said, this 2 will increase by 1 and become a 3. And then for the final step, you replace each digit to the right of the round-off place with a 0. So all we have in this case is a 7 that's to the right of the round-off place. So we just change that to a 0, and we get our answer, which is 230. So 227 rounded to the nearest 10 is 230. Okay, so now let's round 227 to the nearest 100. Okay, to the nearest 100. All right, so again, 227 is the number. But now we're looking at the hundreds place. So we're looking at that 2 there. And then what we want to do is we want to look to the digit to the right of the hundreds place. So we want to look at this 2 here. And in this case, the 2 falls in the category of 4 or less. And when this happens, we leave the digit in the round-off place unchanged. So this 2 will be unchanged. Then for the final step, we replace each digit to the right of the round-off place with a 0. So what we're going to have, the 2 is going to be unchanged. And then the 2 and the 7 here are each to the right of the round-off place. So we're going to change those each into a 0. So the 2 will become a 0, and the 7 will become a 0. And so we get our answer of 200. So 227 rounded to the nearest 100 is 200. Okay, for the next problem, we want to round 65,377 to the nearest 100 and nearest 1,000. So we'll start with this nearest 100. So 65,377. Let's find the hundreds place, and that's going to be right here. And then we're going to look at the digit immediately to the right. So that's going to be this 7 here. And that falls into the category of 5 or larger. And when this happens, we increase the digit in the round off place by 1. So we'll have this 6 and this 5. That's going to stay the same. The 3 increases by 1 and becomes a 4. And then for the final step, we'll replace each digit to the right of the round off place with a 0. So this 7 becomes a 0 and this 7 becomes a 0. Those are both to the right of the hundreds place, which was the round off place. So 65,377 rounded to the nearest hundred is 65,400. Okay, let's talk about rounding it to the nearest 1,000. And I'm just going to erase this real quick. Okay, so now we're going to the nearest 1,000. And so the thousands place is this 5 here. And we want to look at the digit immediately to the right of that. So we're looking at the 3. And 3 falls in the category of 4 or less. So this is going to be unchanged. It's going to be unchanged. And then basically all we're going to do is change everything that follows. So the 3, the 7, and the 7 into a 0. So we will end up with the 6 stays the same. The 5 stays the same. The 3 will become a 0. The 7 becomes a 0. And the 7 becomes a 0. So 65,377 rounded to the nearest 1,000 is 65,000. Okay, now we want to round 10,155,010 to the nearest 1,000 and million. So let's start out by rounding it to the nearest 1,000. The nearest 1,000. So 10,155,010. And where's the thousands place? Well, that's going to be right here. So we're looking at the digit immediately to the right, and that's this 0 here. 0 falls in the category of 4 or less. So that means we leave our digit in the round off place unchanged. Unchanged. So all this stuff to the left of the round off place, we don't have to touch that. So we just copy that. The 5 is unchanged. And then everything that follows will be a 0. So this is already a 0. This 1 will be a 0. And this 0 is already a 0. So 10,155,010 rounded to the nearest 1,000 is just 10,155,000. Okay, let's erase this. We'll look at the other scenario, which is to round it to the nearest million. So where's the millions place? That's going to be right here. So we're looking at that 0 there. Now, we look at the digit that follows the 0, and that's this 1. And 1 again falls in the category of 4 or less. So that means that we leave the digit in the round off place unchanged. And then every digit that follows, we're going to replace with a 0. So this 1 is going to stay the same. The 0 stays the same. And then everything after that's just going to be a 0. So 0, 0, 0, comma, 0, 0, 0. And so 10,155,010 rounded to the nearest million is 10 million. Okay, now we want to round 7,815,319,215 to the nearest billion. So the billions place on this guy is right here. Let me just rewrite the number. It'd be 7,815,319,215. And again, the billions place is right here. And we want to look at the digit that follows that. So we're looking at this 8 here. And that falls in the category of 5 or larger. So when this occurs, we add 1 to the digit in the round off place. So this will be plus 1. And then again, the next step is to replace each digit that follows the round off place with a 0. So all these digits will be a 0. So let's go ahead and write this. The 7, we increase by 1 and it becomes 8. And then all this is going to be 0. So 0, 0, 0, 0, 0, 0, 0, 0, 0. And so 7,815,319,215 rounded to the nearest billion is 8 billion. For the final problem, we want to round 18,375,015,927 to the nearest 100 billion. Okay, so let's just rewrite that. 18,375,015,927. So we're looking for the digit in the 100 billions place. So that's going to be right here. The 3 is in the 100 billions place. Now, looking at the digit to the right of that, we have a 7. And again, that falls in the category of 5 or larger. So that means that we're going to increase the digit in the round off place by 1. Okay, so everything to the left of it is just the same. So we have the 1, then the 8, and then 3 plus 1 would give me 4. And then I'm replacing everything that follows the round off place with a 0. So 0, 0, comma, 0, 0, 0, comma, 0, 0, 0, comma, 0, 0, 0. So 18,375,015,927 rounded to the nearest 100 billion is 18,400 billion. Hello, and welcome to Pre-Algebra Test Section 1 on rounding whole numbers. So for the first problem we're going to look at, we want to round 15,375 to the nearest 10, 100, and 1,000. So we're going to begin by rounding this number to the nearest 10. So we have 15,375. And to round to the nearest 10, we're looking for the digit in the tens place. So that's going to be this 7 here. And then the next thing we want to do is locate the digit to the right of that. So we're looking at this 5 here. Now, when you have the scenario where the digit is 5 or larger, you want to increase the digit in the round off place by 1. So this will increase by 1. So all this to the left of the 7 is the same. The 1, the 5, and the 3. We don't need to change that. We increase the 7 by 1. That becomes 8. And then the final step is to replace each digit to the right of the round off place with a 0. So this number will be 15,380. So that's the answer to round 15,375 to the nearest 10. Again, it's 15,380. Okay, let's look at the next scenario, which is to round the number to the nearest 100. So 15,375. And where's the hundreds place at? That's right here. That's this 3. So now what I want to do is I want to look at the digit immediately to the right of that 3, and that's this 7. 7 again falls in the category of 5 or greater. So we're going to increase the digit in the round off place by 1. And so the 1 and the 5 will stay the same. The 3 will increase by 1 and become 4. And then we want to replace each digit to the right of the round off place with a 0. So the 7 becomes a 0, the 5 becomes a 0. So 15,375 rounded to the nearest 100 is 15,400. Okay, let's erase these and get some room going. And so for the final scenario, we want to round to the nearest 1,000. So 15,375. Where's the thousands place at? That's going to be right here. So let's look at the digit immediately to the right of that. That's this 3. Now the 3 falls in the category of 4 or less. So when this happens, we leave the digit in the round off place unchanged. So unchanged. So we'll have the 1 and the 5 that stay the same. Now, we want to replace each digit to the right of the round off place with a 0. So the 3, the 7, and the 5. So there's our answer. 15,375 rounded to the nearest 1,000 is 15,000. Okay, now we want to round 373,575, again, to the nearest 10, 100, and 1,000. So let's rewrite this number. 373,575. And again, we'll start out by rounding to the nearest 10. So the tens place is right here. That's that 7. And so if I look at the digit immediately to the right of that, I have a 5. And so when the digit is a 5 or greater, we want to increase the digit in the round off place by 1. So this is going to be a +1 here. And so we'll start by just rewriting the 3, the 7, the 3, the 5. And then 7 plus 1 would give me 8. And then as the final step, I replace each digit to the right of the round off place with a 0. So that means I just replace that 5 with a 0. So 373,575 rounded to the nearest 10 is 373,580. Now let's look at the second scenario, which is to round it to the nearest 100. So the hundreds place, if we look, is right here. And then we're looking at the digit immediately to the right of that, and that's this 7. Again, that falls in the category of 5 or greater. So we're going to add 1 to the digit in the round off place. So all this will be the same. The 3, the 7, and the 3. We add 1 to the 5 and we get 6. And then finally we replace each digit to the right of the round off place with a 0. So the 7 and the 5, we'll replace those each with a 0. So it's 373,575 rounded to the nearest hundred is 373,600. Okay, for the last scenario, we want to round to the nearest 1,000. So where's the thousands place here? Well, that's going to be this 3. And we're looking for the digit immediately to the right of that, and we have this 5 here. And again, 5 falls in the category of 5 or larger, so this is going to be plus 1 here. Right? We want to add 1 to the digit in the round off place. So this 3 and this 7 will be the same. We're going to add 1 to the 3 to get 4. And then we'll replace each digit that follows the 3 with a digit in the round off place with a 0. So the 5 becomes a 0, the 7 becomes a 0, and lastly the 5 becomes a 0. And so our answer for 373,575 rounded to the nearest 1,000 is 374,000. Okay, for the final problem, we want to round 21,583, again to the nearest 10, 100, and 1,000. So let's begin by rounding to the nearest 10. And so I'm just going to rewrite this number here, 21,583. So where's the tens place? That's right here. And now I'm looking at the digit that follows. So that's this 3 here. That falls in the category of 4 or less. And when that happens, we leave the digit in the round off place unchanged. Okay, unchanged. So we have the 2, the 1, the 5, and the 8 that are all going to stay the same. And then as the final step, we replace each digit to the right of the round off place with a 0. So that means this 3 becomes a 0. And we get 21,580. So 21,583 rounded to the nearest 10, again, is 21,580. Okay, now let's look at rounding to the nearest 100. And so if we round 21,583 to the nearest 100, we would start by finding the digit in the hundreds place. So that's this 5 here. And then the digit that follows is this 8. 8 obviously falls in the category of 5 or larger. So we're going to increase the digit in the round off place by 1. And so we would have 2, 1, comma, 5 plus 1 would be 6. And then again, we replace each digit that follows the digit in the round off place with a 0. So that becomes a 0, and then that becomes a 0. And 21,583 rounded to the nearest 100 is 21,600. Okay, lastly, let's round to the nearest 1,000. So where's the thousands place at? That's going to be right here. And the digit that follows is going to be this 5 here. So again, that falls in the category of 5 or greater. So that means we increase the digit in the round off place by 1. So this 2 will be the same. 1 plus 1 will give me 2. And then every digit that follows the digit in the round off place, so every digit that follows that 1, we're going to change into a 0. So the 5 becomes a 0, the 8 becomes a 0, and the 3 becomes a 0. So 21,583 rounded to the nearest 1,000 is 22,000. Hello and welcome to Pre-Algebra Test Section 2 on rounding whole numbers. So for the first problem, we want to round 5,273,371 to the nearest 1,000 and 10,000. So let's start out by rounding to the nearest 1,000. And we'll just rewrite this number here. 5,273,371. And the nearest 1,000 means that we're looking for the digit in the thousands place, which is right here. It's that 3. Now, we're looking to the digit immediately to the right of that, and that's a 3 as well. And that 3 falls in the category of 4 or less. So when the digit to the right of the digit in the round off place falls in the category of 4 or less, what you want to do is leave the digit in the round off place unchanged. So this will be unchanged. And so let's rewrite this. Those are all the same. The 3 is going to be the same. And then we're going to replace each digit that follows the digit in the round off place with a 0. So in other words, after this 3, we're going to replace this with a 0, this with a 0, and then this with a 0. And so 5,273,371 rounded to the nearest thousand is 5,273,000. Okay, now let's talk about rounding this number to the nearest 10,000. So all we're doing is we're going one digit to the left. Now we're looking at this 7 here. That's our digit in the 10,000s place. And when we look to the digit to the right of that, we have this 3 here. So again, the 3 is in the category of 4 or less. And when this happens, we leave our digit in the round off place unchanged. So this will be unchanged. So the 5, the 2, and the 7 will be unchanged. So 5, 2, then 7. Now, each digit that follows your digit in the round off place, which is the 7, we're going to change that into a 0. So this 3 will be a 0. Then this 3 will be a 0. Then the 7, and then the 1. So 5,273,371 rounded to the nearest 10,000 is 5,270,000. For the next one, we want to round 65,315 to the nearest 1,000 and 10,000. So we'll start with rounding to the nearest 1,000. So again, we have 65,315. And the thousands place is going to be right here. So we're looking for the digit immediately to the right of that. And again, we have a 3. And 3 falls in the category of 4 or less. So this 5 is going to be unchanged. Unchanged. So the 6 and the 5 are both going to stay the same. And then we're going to replace each digit that follows that 5, the digit in the round off place, with a 0. So 0, 0, 0. So 65,315 rounded to the nearest 1,000 is 65,000. Okay, next let's look at rounding this to the nearest 10,000. So the 10,000s place is going to be right here. So that's going to be that 6 there. And we want to look at the digit to the right of that. So that's going to be this 5 here. So that falls in the category of 5 or greater. So that means we're going to add 1 to the digit in the round off place. So we're adding 1 to the 6. So that's going to become 7. Now, each digit that follows that 6, again, the digit in the round off place, is going to be changed to a 0. So the 5, the 3, the 1, and the 5. So 65,315 rounded to the nearest 10,000 is 70,000. Okay, for the last one, we want to round 26,300, again, to the nearest 1,000 and 10,000. So we're going to begin by rounding to the nearest 1,000. So 26,300. And where's the thousands place? That's going to be right here. And the digit that follows, again, is a 3. And that falls in the category of 4 or less. So we're going to leave this digit unchanged. Unchanged. So the 2 and the 6 will be the same. And then we're going to replace everything that follows the 6, again, the digit in the round off place, with a 0. So the 3, we're going to change that to a 0. And then these are already 0, so we're just going to copy those. So we end up with 26,000 for the answer. And again, it's 26,300 rounded to the nearest 1,000, and that gives us 26,000. Okay, now let's round to the nearest 10,000. And so the 10,000s place is right here. So we're looking at that 2 for the 10,000s place. We go one digit to the right, and we have this 6 here. And the 6 falls in the category of 5 or greater. So again, when this happens, we add 1 to the digit in the round off place. So that 2 will become a 3. And then we'll replace every digit that follows with a 0. So the 6 becomes a 0, the 3 becomes a 0, and then these are already zeros. So we end up with 30,000 as our answer. And again, for rounding 26,300 to the nearest 10,000. Hello and welcome to Pre-Algebra Test Section 3 on rounding whole numbers. For the first problem, we want to round 6,375,322 to the nearest million. So let's rewrite this number, 6,375,322, and we're looking for the millions place, right? We're rounding to the nearest million. So that's going to be this 6 right here, and then we're looking to the digit immediately to the right of that, and that's this 3 here. 3 falls in the category of 4 or less. So when this happens, you want to leave your digit in the round off place unchanged. So this will be unchanged. So this will just be a 6. And then you're going to replace every digit that follows the digit in the round off place with a 0. So essentially 0, 0, 0, comma 0, 0, 0. So 6,375,322 rounded to the nearest million is 6 million. Okay, for the next problem, we want to round 17,955,971 to the nearest million. So let's rewrite that. 17,955,971. And again, we're rounding to the nearest million. So we're looking for the digit in the millions place, and that's going to be this 7 here. So if we look at the digit immediately to the right of that, we have a 9. And when we have a digit like 9, it falls in the category of 5 or greater, and that tells us to add 1 to the digit in the round off place. So this 1 will be the same. 7 plus 1 is 8. And then we're going to replace every digit that follows that digit in the round off place, the 7, with a 0. So this will be a 0, a 0, a 0, comma. We have another 0, and lastly, another 0. So 17,955,971 rounded to the nearest million is 18 million. Okay, for the last problem, we want to round 19,100,571 to the nearest million. So 19,100,571, and again, we're rounding to the nearest million. So that's going to be right here. That 9 is in the millions place. And so we're looking at the digit immediately to the right, and that's a 1. And the 1 falls again in the category of 4 or less. When that happens, we leave our digit in the round off place unchanged. And so the 1 and the 9 will stay the same. And then every digit that follows that 9, again, the digit in the round off place, we're just going to turn that into a 0. So the 1 becomes a 0. These two are already zeros. And then the 5, the 7, and the 1 will make those each into a 0. So 19,100,571 rounded to the nearest million is 19 million. Hello and welcome to Pre-Algebra Test Section 4 on rounding whole numbers. So for the first problem today, we'd like to round 163,517,325,317 to the nearest billion. Okay, so to the nearest billion. Let's just rewrite this number. So again, 163,517,325,317. So where's the billions place at here? Well, it's going to be right here. It's going to be this 3. And we want to look at the digit that follows the digit in the round off place. So that's going to be this 5 here. And then the 5 falls into the category of 5 or greater. And so what we do is we add 1 to the digit in the round off place. So the 1 and the 6 will stay the same. 3 plus 1 gives me 4. And then as the final step, we want to replace each digit to the right of the round off place with a 0. So everything to the right of a 3 is going to be a 0. So 0, 0, 0, comma, 0, 0, 0, comma, 0, 0, 0. So 163,517,325,317 rounded to the nearest billion is 164 billion. Okay, now we want to round 224,978,381,500 to the nearest billion. Okay, so again, to the nearest billion. All right, let's just rewrite this number here. So again, we have 224,978,381,500. So where's the billions place? It's going to be right here. Then we want to look at the digit that follows that. So that's going to be this 9. And the 9 falls in the category of 5 or greater. So that means we add 1 to the digit in the round off place. So this 2 and this 2 will stay the same. 4 plus 1 gives me 5. And then we replace everything to the right of the 4, the digit in the round off place, with a 0. So we'll have 0, 0, 0, 0, 0, 0, 0, 0, 0. So 224,978,381,500 rounded to the nearest billion is 225 billion. Okay, for the final problem, we have 6,536,179, and we want to round this to the nearest billion. Okay, again, rounding to the nearest billion. So 6,536,179. So the billions place is here. It's this 0. And the digit to the right of that is a 0 as well. So that falls in the category of 4 or less. And when this happens, we leave the digit in the round off place unchanged. So unchanged. So what's going to happen is this 6 is going to stay the same. Then these 3 zeros will be the same. And then everything to the right of this 0 here in the billions place, we're going to change into a 0 if it's not already a 0. So we'll have 0, 0, 0, comma, 0, 0, 0, comma, 0, 0, 0. So 6,536,179 rounded to the nearest billion is 6 trillion. Hello and welcome to Pre-Algebra Test Section 5 on rounding whole numbers. So for the first problem, we want to round 169,315,111,827,059 to the nearest 10 trillions. So 10 trillions. Let's just rewrite this number. 169 trillion, 315 billion, 111 million, 827,059. So the 10 trillions place is going to be right here. That's this 6. So if we look at the digit that follows, that's this 9. 9 falls in the category of 5 or greater. So that means we're going to add 1 to the digit in the round off place. So that 6 is going to become a 7. So this 1 is going to be unchanged. Again, the 6 becomes a 7. And then everything to the right of the 6, we're going to replace with a 0. So then we'll just have 0, comma, 0, 0, 0, comma, 0, 0, 0, comma, 0, 0, 0, comma, 0, 0, 0. So 169 trillion, 315 billion, 111 million, 827,059 rounded to the nearest 10 trillions is 170 trillion. Okay, next we want to round 5 quadrillion, 978 trillion, 181 billion, 246 million, 56,192 to the nearest 10 trillions. So let's rewrite this. 5 quadrillion, 978 trillion, 181 billion, 246 million, 56,192. So the 10 trillions place is going to be right here. It's going to be that 7. And if we look at the digit that follows, it's going to be this 8 here. So that falls in the category of 5 or greater. So we're going to add 1 to the digit in the round off place. So this 5, this 9 will stay the same. The 7 plus 1 will give us 8. And then everything that follows the 7, again, the digit in the round off place, we're going to change into a 0. So this will be a 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0. So 5 quadrillion, 978 trillion, 181 billion, 246 million, 56,192 rounded to the nearest 10 trillions is 5 quadrillion, 980 trillion. Hello and welcome to Pre-Algebra Practice Set number 5. In this video, we're going to look at some additional practice problems for the lesson that we did on properties of addition. So for the first set of problems we're going to look at, we want to use the commutative property to rewrite each sum. So the commutative property of addition tells us that we can add in any order without changing the sum. So starting with 2 plus 9, I could rewrite this as 9 plus 2. Because in this case, 2 is first and 9 is last, if we think about the order of the add-ins. And when I say add-ins, I mean the numbers that are being added together. The commutative property, again, tells us that we can switch that around and still get the same result. So instead of 2 being first, now 9 is first and 2 is last. So 2 plus 9 gives us the same result as 9 plus 2. In each case, you get 11. 2 plus 9 equals 11. 9 plus 2 equals 11 as well. Okay, for another one, we have 7 plus 15. So to rewrite this, we would just switch the order, and we would put 15 plus 7. And in each case, you'd be looking at 22, right? 7 plus 15 equals 22. And 15 plus 7 equals 22 as well. Again, the order does not change the sum. Now we have 12 plus 3. Again, just change the order around. So we're going to write this as 3 plus 12. So 12 plus 3 equals what? Equals 15. And 3 plus 12 equals 15 as well. Okay, we'll look at 2 more. So we have 6 plus 2. So again, change the order around. We'll make that 2 plus 6. And in each case, that's 8, right? 6 plus 2 equals 8. And 2 plus 6 equals 8 as well. Okay, for the final one, we have 8 plus 5. And again, we're just going to switch the order around. So we'll write this as 5 plus 8. And again, it's the same answer either way. 8 plus 5 is 13. And 5 plus 8 is 13 as well. Okay, now for the next set of problems, we want to use the associative property to rewrite each sum. So the associative property of addition tells us that the addition of 3 or more numbers can be grouped in any order without changing the sum. So for example, here we have 3 plus 5 plus 2. Now notice how we have 3 plus 5 inside of parentheses. So we could refer to this as the quantity 3 plus 5. We could rewrite this as 3 plus 5 plus 2, where we put parentheses around 5 plus 2 now. So we'd have 3 plus the quantity 5 plus 2. Notice how the numbers that we're adding are the same, 3 plus 5 plus 2. All we did was we just changed what we had parentheses around. So in this case, we have parentheses around 3 plus 5. Here we have parentheses around 5 plus 2. And as I told you in a lesson, we haven't gotten to the order of operations yet, but essentially, when you have parentheses, you want to do what's inside of the parentheses first. So if we were to evaluate each side, we think about what's on the left. 3 plus 5 would be done first because it's inside of parentheses. So that would give us 8. So you'd have 8 plus 2. That would give you 10. So essentially, the left side would be 10. If we look at the right side, we do 5 plus 2 first because that's what's in parentheses now. 5 plus 2 is 7. So we'd have 3 plus 7, and that equals 10 as well. So either way you do it, you're going to get the result of 10. And that's, again, what the associative property of addition is telling us. Okay, for the next problem, we have 9 plus 7 inside of parentheses. So we'll go ahead and just say that's the quantity 9 plus 7, then plus 8. Okay, so the quantity 9 plus 7 plus 8. So we want to use the associative property of addition to rewrite this. So it's going to be the same numbers. So 9 plus 7 plus 8. We're just going to change what we have parentheses around. So here we have parentheses around 9 plus 7. Here we'll put parentheses around 7 plus 8. And so we rewrite it. But the sum is going to be the same either way. So 9 plus 7 would be done first here on the left because it's inside of parentheses. That's 16. Then 16 plus 8 is 24. Over here on the right, 7 plus 8 would be done first because now that's what's inside of parentheses. 7 plus 8 is 15. And then we'd add 9 to that. 15 plus 9 is, again, 24. So again, another example where we changed what we had parentheses around, but it didn't matter. We're adding the same 3 numbers, and that's what the associative property of addition is telling us. Okay, for the next example, we have 6 plus the quantity 1 plus 4. And again, parentheses around 1 plus 4 there. So we're going to rewrite this using the associative property. Basically just going to put parentheses around different numbers. So we'll write 6 plus 1 plus 4. Those are the 3 numbers that are being added together. I'm just, again, going to change what I have parentheses around. So now we're going to put parentheses around 6 plus 1. Let me just highlight that. And to prove that you get the same result, on the left I do 1 plus 4 first because that's what's inside of parentheses. 1 plus 4 is 5. So we'd have 6 plus 5, that's 11. On the right, we do 6 plus 1 first because that's what's inside of parentheses. 6 plus 1 would give me 7. Then 7 plus 4, again, would give me 11. So we're getting the same answer. Okay, here we have the quantity 3 plus 5, then plus 3. So again, parentheses are around 3 plus 5. And to rewrite this using the associative property, we're going to use the same numbers. So 3 plus 5 plus 3. We're just going to change where we have our parentheses. So now I'm going to put parentheses around 5 plus 3. And again, just to prove to you that you get the same result, 3 plus 5 on the left would be done first because that's what's inside of parentheses. 3 plus 5 is 8. Then we'd add 3 to that. 8 plus 3 is 11. On the right, we'd do 5 plus 3 first. 5 plus 3 is 8. 8 plus 3 again is 11. Now we have 6 plus the quantity, 2 plus 13. And 2 plus 13 here is inside of parentheses. So let's rewrite this as 6 plus 2 plus 13, where we put parentheses around 6 plus 2 now. So the quantity 6 plus 2 plus 13. And again, just changing what we have parentheses around. The numbers that we're adding are still the same. We're still adding 6, 2, and 13 together. That doesn't change. Just changing what we put parentheses around. And again, to prove that we get the same result either way, on the left, we'd start with 2 plus 13. That's what's inside of parentheses. 2 plus 13 is 15. And then we'd add 6 to that. 15 plus 6 is 21. Over here on the right, 6 plus 2 is 8. And then 8 plus 13 is 21 as well. Okay, now we want to find each sum. So the problems we're going to look at here deal with the identity property of 0. And the identity property of 0 just tells you that you can add 0 to a number and the number stays unchanged. So in this example, we have 3 plus 0 equals what? Again, we're adding 0 to 3. 3 is not going to change. So 3 plus 0 equals 3. Here we have 1,759,373 plus 0. It doesn't matter that I used a relatively large number. Adding 0 to a number doesn't change it. So I'm just going to use this number as the result. 1,759,373. Okay, so for the last one here, we have 0 plus 12,335,988,642. So it doesn't matter how big the number is, because it's a relatively large number. The rule for adding 0 to a number holds for all real numbers. So we would just get this number back. So the answer would be 12,335,988,642. Okay, for the last set of problems we're going to look at, we want to identify the parts of each addition problem. And essentially, we want to label each as either an add-in or a sum. So the add-ins are the numbers that are being added together. So being combined together through the addition process. The sum is the result. So when we look at 3 plus 6 equals 9, when we want to label the parts of the addition problem, the numbers being added together, those are the add-ins. So these are the add-ins. The result of the addition is the sum. So 9 is the sum. It's the result when we add 3 and 6 together. Okay, here we have 9 plus 8 plus 15 plus 12 equals 44. So the numbers being added together, the 9, the 8, the 15, and the 12, those are the add-ins. And then the 44, which is the result of the addition, is the sum. Okay, final problem. We have 0 plus 5 plus 2 plus 8 equals 15. Again, the numbers being added together, 0, 5, 2, and 8, these are the add-ins. And then the result of the addition, 15, is the sum. Hello, and welcome to Pre-Algebra Test Section 1 on Properties of Addition. So for the problems we're going to look at today, we want to rewrite each using the commutative property. So the commutative property of addition tells us that we can add in any order that we want, and it's not going to change the sum. So let's take a look at the first part. We have 1 plus 7. So essentially, to rewrite this using the commutative property, we just change the order of the add-ins. And again, the numbers being added together, those are called add-ins. So instead of 1 plus 7, we'll just have 7 plus 1. Again, all I did was I just switched the order. And you can see that the result will be the same either way. 1 plus 7 is equal to 8, and 7 plus 1 is equal to 8 as well. For the next one, we have 2 plus 4. Again, all we're doing is we're just changing the order. So we'll write this as 4 plus 2. And we know that 2 plus 4 equals 6. And we know that 4 plus 2 equals 6 as well. Okay, next we have 6 plus 15. So we're going to rewrite this as 15 plus 6. Again, just switching the order. And 6 plus 15 is 21. And so is 15 plus 6. Right? Changing the order does not change the sum. So one final problem. We have 13 plus 12. And we're just going to change the order of the add-ins. So we're just going to put 12 first, then plus 13. And again, it's the same result either way. 13 plus 12 equals 25. And 12 plus 13 equals 25 as well. Hello and welcome to Pre-Algebra Test Section 2 on Properties of Addition. So for the problems we're going to look at, we're going to rewrite each using the commutative property. So the commutative property of addition, again, tells us that we can add in any order that we want, and we're not going to change the sum. So we start with 21 plus 1. When you get a problem like this, all you want to do is just change the order of what we call the add-ins. The numbers being added together are called add-ins. So we're going to change the order. Instead of 21 being first, we're going to make it last. And we're going to put 1 first. So we're going to put 1 plus 21. So we switch the order of the addition, but the sum is not going to change. The result from the addition is the same. So 21 plus 1 equals 22. 1 plus 21 equals 22 as well. What about 13 plus 9? Again, just switch the order. So this will be 9 plus 13. And again, just to prove to you that the commutative property of addition works, 13 plus 9 is 22, and 9 plus 13 is 22 as well. Okay, now we have 51 plus 7. And again, to rewrite this using the commutative property, just switch the order. So we'll have 7 plus 51. And 51 plus 7 equals 58. And 7 plus 51 equals 58 as well. Okay, final problem, we have 103 plus 2. Again, we can rewrite this using the commutative property by switching the order. So we'll put 2 plus 103. And 103 plus 2 equals 105. And it's the same when we switch the order. 2 plus 103 equals 105 as well. Hello and welcome to Pre-Algebra Test Section 3 on Properties of Addition. So what we want to do for these problems, we want to identify the parts of each addition problem. So when we look at an addition problem, you have two parts. You have the add-ins, and the add-ins are the numbers that are being added together. And then you have the sum, which is the result from the addition. So let's take a look at the first one. So we're going to begin with 9 plus 4 equals 13. So we're going to label the 9 and the 4 as the add-ins. Okay, the add-ins. These are the numbers that are being combined together through addition. The result of 9 plus 4 is 13. So 13 is your sum. Okay, 13 is the sum. Next we have 12 plus 10 equals 22. So again, the numbers being added together, the 12 and the 10, those are the add-ins. So these are the add-ins. And the result of the addition, 12 plus 10, is 22. 22 is your sum. Okay, now we have 5 plus 4 plus 11 plus 3 equals 23. So the numbers being added together, the 5, the 4, the 11, and the 3, those are the add-ins. So these are the add-ins. And then 23 is the result of the addition. This is the sum. Okay, for the next set of problems, we're asked to find each sum. And these problems deal with the identity property of 0, which tells us we can add 0 to any number, and the number will remain unchanged. So let's take a look at what we have. We have 37 plus 0, and of course that's just going to be 37. Adding 0 to 37 doesn't change it, so you just get 37. Here you have 0 plus 962. That's just going to be 962. Again, adding 0 does not change the number. Okay, for the last one, we have 1,362,373 plus 0. And again, adding 0 to a number does not change it, so you get 362,373 as the answer. Hello and welcome to Pre-Algebra Test Section 4 on Properties of Addition. So for these problems, we want to rewrite each using the associative property. So the associative property of addition tells us that when we're adding 3 or more numbers, we can group this addition any way that we'd like, and we're not going to change the sum. So let's take a look at the first one here. And we have 3 plus 1 plus 5. Notice how 3 plus 1 is inside of parentheses. So we're just going to go ahead and say that this is the quantity 3 plus 1, then plus 5. So how would we rewrite this using the associative property? Well, we're going to use the same 3 numbers. So 3 plus 1 plus 5. We're just going to put parentheses around different numbers. So instead of there being parentheses around 3 plus 1, we're going to put parentheses around 1 plus 5. And just to test out that the associative property is true, let's go ahead and evaluate each side and see what we get. Now, we do whatever is inside of parentheses first. So on this side, we do 3 plus 1 first. So 3 plus 1 would give me 4, and then I'd have plus 5, and 4 plus 5 would give me 9. On the right side, what we have inside of parentheses is 1 plus 5. So we're going to do that first. 1 plus 5 is 6, so we would have 3 plus 6. That gives me 9 as well. So either way we get 9, even though we put 3 plus 1 here in parentheses, and we put 1 plus 5 over here in parentheses, it didn't matter. And that's exactly what the associative property of addition tells us. Okay, for the next problem, we have 17 plus the quantity 11 plus 2. And again, I said the quantity 11 plus 2 because it's inside of parentheses. So we're going to rewrite this using the associative property. Again, using the same 3 numbers. So 17 plus 11 plus 2. I'm just going to change what I have parentheses around. Here I have parentheses around 11 plus 2. Here I'm going to put parentheses around 17 plus 11. But again, I get the same result either way. On the left, if I do 11 plus 2 first, I get 13. Then I add that to 17, I'm going to get 30. On the right, what's in parentheses is 17 plus 11. 17 plus 11 is 28. Then if I add 28 and 2 together, I get 30 as well. So again, it doesn't matter that we have parentheses around different numbers. We get the same result. Okay, last problem. We have the quantity 9 plus 2, then plus 1. So the quantity 9 plus 2, and again, I'm saying it that way because 9 plus 2 is inside of parentheses. And to rewrite this using the associative property, again, use the same 3 numbers. So 9 plus 2 plus 1. I'm just going to shift what I have parentheses around. So instead of it being around 9 plus 2, I'm going to put it around 2 plus 1. And again, we're going to get the same result. On this side, I do 9 plus 2 first because that's in parentheses. 9 plus 2 is 11. Then I add 1 to that, so I'd get 12. On this side, I'd do 2 plus 1 first. 2 plus 1 is 3. And then I'd add that to 9. 9 plus 3 is 12. So either way, I get 12. And again, this is what the associative property of addition is telling us. It doesn't matter what we're putting parentheses around. When we're just simply adding, you're going to get the same result either way. Hello and welcome to Pre-Algebra Test Section 5 on Properties of Addition. So for these problems, we want to rewrite each using the associative property. So again, the associative property of addition tells us that when we're adding 3 or more numbers, we can group this addition in any way that we'd like, and it's not going to change our sum. So we're going to begin with the quantity 4 plus 6. And I say the quantity 4 plus 6 because there's parentheses around 4 plus 6. So the quantity 4 plus 6 plus 7. How would we rewrite this using the associative property? Well, we're going to use the same 3 numbers. So the 4, the 6, and the 7. So the addition part is the same. It's still 4 plus 6 plus 7. What we're changing is the grouping. So what we have parentheses around. So instead of having parentheses around 4 plus 6, we're going to put parentheses around 6 plus 7. So now we'd have 4 plus the quantity 6 plus 7. But what the associative property of addition is telling us is that it doesn't matter how you group the addition, the result is going to be the same. On the left, we have 4 plus 6 inside of parentheses, so when we evaluate, we would do that first. So 4 plus 6 would give us 10. So we would essentially have 10 plus 7, which is 17. So this side is 17. On the right, we would do 6 plus 7 first because now that's inside of parentheses. 6 plus 7 is 13. So we would have 4 plus 13, and that is 17 as well. So you can see it does not matter what you put parentheses around if you're adding the same three numbers. You get the same result either way. Okay, now we want to look at 13 plus the quantity 2 plus 8. So we have parentheses around 2 plus 8. And so I'm just going to rewrite this, 13 plus 2 plus 8. And I'm just going to put parentheses around different numbers. So instead of it being around 2 plus 8, we'll put it around 13 plus 2. And again, to show you that you get the same result either way, 2 plus 8 is 10. 10 plus 13 is 23. Over here, 13 plus 2 is 15. 15 plus 8 is 23 as well. Okay, for the last one we have the quantity 10 plus 20, then plus 15. Again, parentheses around 10 plus 20. And we're rewriting this using the associative property of addition. So we have 10 plus 20 plus 15. And we're just going to shift what we have parentheses around to 20 plus 15. Again, to prove that this property holds, if we look at the left side, we do 10 plus 20 first because it's in parentheses. 10 plus 20 is 30. Then we add 15 to the result. That gives us 45. Over here we have 20 plus 15. That would be done first because that's what's inside of parentheses. 20 plus 15 is 35. Then we add 10 to that. We would get 45 as well. So you can see either way, you get 45 as your answer. And changing what we had parentheses around didn't make a difference. And that's, again, what the associative property of addition is telling us. Hello, and welcome to Pre-Algebra Practice Set number 6. And in this video, we're going to look at some additional practice problems for the lesson that we did on adding whole numbers using a number line. Okay, so to begin, we want to add each using a number line. And we start out with the first problem. It's 7 plus 4. So when we perform addition of whole numbers on a number line, essentially we just take the leftmost number of the addition problem and we start there on the number line. So our leftmost number is a 7, so we locate 7 on the number line and we just start there. Then we're adding 4. So that means we're just moving to the right 4 units on the number line. So I'm going to move 1, 2, 3, 4 units to the right, and I end up at 11. Okay, so we all know that 7 plus 4 is 11. So let me just write that here. 7 plus 4 equals 11. Now we have 3 plus 1 plus 5. And even though we're adding 3 numbers, we're going to do the same thing. We're going to start at the leftmost number, which is 3, on the number line. And then every time we add a number, we're just going to move to the right on the number line by that number of units. So we're adding 1, so we just go 1 unit to the right. So that will put us at 4. And then we're adding 5, so now we're going to go 5 units to the right. So I'm going to go 1, 2, 3, 4, 5 units to the right, and we end up at 9. So we end up at 9, so 3 plus 1 plus 5 equals 9. And you can check that in your head. 3 plus 1 is 4, 4 plus 5 is 9, so we can see that that is correct. For the next problem, we have 12 plus 5 plus 2. So again, we're going to start at the leftmost number on the number line, so we'll start at 12. So that is going to be right here. And then we're adding 5, so that means we're moving to the right by 5 units. So we're going 1, 2, 3, 4, 5 units to the right. So that's going to put us at 17. Now we're adding 2 to that, so we're going to go another 2 units to the right. So 1, 2 units to the right, and that gives us a final answer of 19. So 12 plus 5 plus 2 equals 19. And just check that in your head. 12 plus 5 is 17. 17 plus 2 is 19. Yeah, that checks out. Okay, for the final problem we're going to look at, we have 9 plus 1 plus 4 plus 6. Again, even though it's 4 numbers now that we're adding, the procedure is still going to be the same. Start out at the leftmost number on your number line. So here's 9 here. And we want to move to the right by the number of units that we're adding. So if we're adding 1, we're moving to the right 1 unit. So that puts us at 10. Then we're adding 4. So we're moving to the right 4 units. 1, 2, 3, 4. So that is 14. And then we're adding 6. So now we're moving to the right 6 units. 1, 2, 3, 4, 5, and 6. and that gives us a final answer of 20. So 9 plus 1 plus 4 plus 6 is equal to 20. We can just mentally check that. 9 plus 1 is 10, 10 plus 4 is 14, and 14 plus 6 is in fact 20. Hello, and welcome to Pre-Algebra Test Section 1 on adding whole numbers using a number line. So for our problems, we want to add each using a number line. So we're going to start with the problem 1 plus 4. So basically when we add whole numbers using a number line, we take our leftmost number from the addition problem and we start there on the number line. So we're going to start out at 1, which is our leftmost number from the addition problem. And then when we add a whole number, we just move to the right on the number line by that number of units. So we're adding 4, so we're just going to go 1, 2, 3, 4 units to the right, and we end up at 5. So 1 plus 4 equals 5, and we all know that that is true. Okay, now we want to work on 2 plus 6. So again, we want to start at the leftmost number of the addition problem, which is 2 on our number line. And then we're adding 6, so we're just moving 6 units to the right on the number line. So 1, 2, 3, 4, 5, 6. And of course, we end up at 8, right? Because 2 plus 6 is equal to 8. Okay, for the final problem, we're adding 3 numbers. And essentially, we're just using the same technique. Starting at the leftmost number on the number line, and then every time we add a whole number, we just move to the right on the number line by that number of units. So if we have 5 plus 2 plus 3, 5 is the leftmost number of the addition problem. We're going to start there on the number line. We're adding 2, so we're just going 1, 2 units to the right to end up at 7. And then we're adding 3, so we're just going to go 1, 2, 3 units to the right, and we end up at 10 on our number line. So 5 plus 2 plus 3 is equal to 10. And of course, we can mentally check that. 5 plus 2 is 7. 7 plus 3 is in fact 10. Hello, and welcome to Pre-Algebra Test Section 2 on adding whole numbers using a number line. So for the problems today, we just want to add each using a number line. So we're going to begin with 1 plus 3 plus 2. And basically the way this works is you start at the leftmost number. So you start out at 1 on the number line. So that's right here. And then every time you add a number, you're going to move to the right by that number of units on the number line. So we're adding 3 to 1. So we're just going to move 3 units to the right. So 1, 2, 3 units to the right. That would put us at 4. And then we're adding 2 more. So we're going to move 2 more units to the right on the number line. So 1, 2, and that's going to put us at 6. So the answer for 1 plus 3 plus 2 is 6. 1 plus 3 plus 2 equals 6. And you can kind of mentally check this. 1 plus 3 gives you 4. 4 plus 2 does give you 6. Okay, for our last problem, we have 6 plus 2 plus 4. Again, we're going to start out on the number line at the leftmost number. So we're going to find 6, and that's right here. And we're going to move to the right 2 units to add 2. So we're adding 2. So that puts us at 8. And then we're adding 4. So we're going to move 4 units to the right. So 1, 2, 3, 4. So that puts us at 12. So 6 plus 2 plus 4 equals 12. And again, you can mentally check that. 6 plus 2 is 8. 8 plus 4 is 12. Hello, and welcome to Pre-Algebra Test Section 3 on adding whole numbers using a number line. So for our problems today, we want to add each using a number line. Okay, so we begin with 4 plus 3 plus 5 plus 1. So when we add whole numbers using a number line, we start on the number line at the leftmost number of the addition problem. So we're going to start out at this 4. Every time we add a number, we're going to move to the right by that number of units. So we're adding 3. We're going to go to the right 1, 2, 3 units. So we're going to end up at 7. Then we're adding 5. So we add 5. We're going to go 5 units to the right. 1, 2, 3, 4, 5. That's going to put us at 12. And then lastly, we're adding 1 more. So we're going to go 1 more unit to the right, and that's going to give us 13. So the answer for our addition problem, 4 plus 3 plus 5 plus 1, is 13. And let me just highlight that here. So started at 4 and went to 13. And again, you can check this mentally. 4 plus 3 is 7, 7 plus 5 is 12, and 12 plus 1 is in fact 13. Okay, last one. we have 7 plus 1 plus 5 plus 1. So again, start at the leftmost number of the addition problem. So start at 7 on the number line. And then every time we add a number, we're going to move to the right by that number of units. So we start by adding 1. So we're going to go to the right 1 unit. That puts us at 8. Now we're going to add 5. So we're going to go 5 units to the right. So 1, 2, 3, 4, 5. That's going to put us at 13. And then lastly, we add 1. So we're going to go 1 more unit to the right. And that's going to put us at 14 as our final answer. Let me highlight that guy. So we have 7 plus 1 plus 5 plus 1 equals 14. And again, you can mentally check it. 7 plus 1 is 8. 8 plus 5 is 13. 13 plus 1 is, in fact, 14. Hello, and welcome to Pre-Algebra Test Section 4 on adding whole numbers using a number line. So for these exercises, we want to add using a number line. And we're going to start with 9 plus 4 plus 3 plus 1 plus 2. And again, we want to start out at the leftmost number of the addition problem, and we're going to find that on the number line. So we start out at 9. And every time we add a number, we're just moving to the right by that number of units on the number line. So if we're going to add 4, we're just going 4 units to the right on the number line. So that's 1, 2, 3, and 4. So we're going to end up at 13. Then we're adding 3. So we're going to go 1, 2, 3. So we end up at 16. Then we're adding 1. So we're just going 1 unit to the right. So that's 17. And then we're adding 2. So to add 2, we're going 2 units to the right. So 1, 2. And we end up at 19 as our final answer. So 9 plus 4 plus 3 plus 1 plus 2 is equal to 19. And again, you can kind of mentally check this. 9 plus 4 is 13. 13 plus 3 is 16. 16 plus 1 is 17. 17 plus 2 is, in fact, 19. Hello, and welcome to Pre-Algebra Test Section 5 on adding whole numbers using a number line. So for the problems we're going to look at today, we want to add using a number line. So our problem is 10 plus 2 plus 4 plus 6 plus 1. So to add whole numbers using a number line, we're going to start at the leftmost number of your addition problem on the number line. So here's 10 on the number line. Now every time we add a number, we just move to the right by that number of units on the number line. So we're adding 2. So we're just going to go 1, 2 units to the right on the number line. So that puts us at 12. Then we're adding 4. So that's going to put us 1, 2, 3, 4 units to the right on the number line. So at 16. Then we're adding 6. So that's going to put us 1, 2, 3, 4, 5, 6 units to the right on the number line. So at 22. And lastly, we're adding 1. So we're just going to go 1 more unit to the right on the number line. And that puts us at 23. 23. Let's write our answer. 10 plus 2 plus 4 plus 6 plus 1 is equal to 23. And you can mentally check that. 10 plus 2 is 12. 12 plus 4 is 16. 16 plus 6 is 22. And then 22 plus 1 is 23. Hello, and welcome to Pre-Algebra Practice Set number 7. And in this video, we're going to look at some additional practice problems for the lesson that we did on vertical addition. So the instructions for today, we want to just perform each addition. So we're going to begin with 62 plus 55. So remember, we're going to stack these numbers on top of each other. And we got to make sure we line them up by place value. So we'll have 62 plus 55. And again, remember, it's got to be by place value. So this is all the numbers that are in the ones place are going to go here. And then all the numbers in the tens place are going to go here. They got to be lined up. So now we perform our addition. And we start in the rightmost column or the ones column, and we work to the left. So we start with 2 plus 5. That's 7, so we're going to put that in the ones column for the answer. We just go straight down. We're moving to the left now. So we're going to the next column left. That's the tens column. And we're going to do 6 plus 5. That's 11. So we just write a 1 in the tens column. And we would usually carry a 1 into the next column up here, but there's no more numbers, so we just write it here. So we get an answer of 117 for 62 plus 55. Okay, next we have 5,092 plus 7,001. So 5,092 plus 7,001. Okay, so again, we're going to start with the numbers in the ones column. We're just going to go straight down. So 2 plus 1 is 3. We put that result in the ones column for the answer. Again, just going straight down. Now we're moving to the left. So now we're going to do 9 plus 0. 9 plus 0 is 9. Moving to the left again, 0 plus 0 is 0. Moving to the left again, 5 plus 7 is 12. We can go ahead and write a 12 here because there's no more numbers to the left. So we're just putting a 2 in the thousands place and a 1 is going into the 10,000s place. So our answer here is 12,093. Okay, now we have 343,221 plus 6,341,592. Typically, when we have numbers that have a different number or a different amount of digits in them, we take the number that has the most digits and we put that on top. You don't have to do that. You can do it either way. But this is generally how we're going to do that. We're going to put 6,341,592 on top, and we're going to put 343,221 on the bottom. And again, make sure you line them up by place value, and you just work right to left. So we're going to start in the ones column. 2 plus 1 is 3. And we're going to the tens column. 9 plus 2 is 11. Now remember, 11 is too big to fit in this space here. Okay? So what we do is we put a 1 down. We put a 1 down, and we carry a 1. Okay? We carry a 1. Essentially, when you have 11, you take the rightmost digit, and you put in the answer column, and then you carry the leftmost digit into the next column, and that's what we've done. Okay, so now we're going to continue our addition. So now we have 1 plus 5, that's 6. 6 plus 2 is 8. Then we go 1 plus 3, that's 4. Then we have 4 plus 4, that's 8. Then 3 plus 3 is 6. And then this 6 we can just bring down. So we end up with 6,684,813 as our answer. Okay, for the next problem, we have 99,672 plus 3,357 plus 115,799. And essentially, this is a little bit new for us because we haven't done one with 3 add-ins in it, or 3 numbers that are being added. But it's the same. I'm just going to start by putting the numbers on top of each other. I'm going to stack them up. And I'm going to take the number with the most amount of digits, which is 115,799, and I'm going to put that on top. Then I'm going to go to the number with the second most amount of digits in it, which is 99,672. Put that in the middle. And then I'm going to take 3,357, and I'm going to put that guy on the bottom. Okay, so let's do some addition here. So I'm going to start in the right column, which is the ones column, and I'm going to add. 9 plus 2 is 11. 11 plus 7 is 18. So I'm going to put an 8 here, which is the rightmost digit of 18, and I'm going to carry a 1. I'm going to carry a 1. Okay, now we're going to do 1 plus 9, that's 10. 10 plus 7 is 17. 17 plus 5 is 22. So I'm going to put a 2 into the answer column, the rightmost digit, and I'm going to carry a 2 into the next column. So now we have 2 plus 7, that's 9. 9 plus 6 is 15. 15 plus 3 is 18. Okay, so I'm going to put an 8 down into the answer column, and I'm going to carry a 1. So now we move it to the next column. 1 plus 5 is 6. 6 plus 9 is 15. 15 plus 3 is again 18. So I'm putting an 8 down in the answer column, and I'm carrying a 1 over into the next column. 1 plus 1 is 2. 2 plus 9 is 11. So again, putting a 1 down and carrying a 1. Okay, carrying a 1. And now I just have 1 plus 1, and that's 2. So I can bring that down here. I end up with 218,828 as the answer. Hello and welcome to Pre-Algebra Test Section 1 on vertical addition. So for the problems today, we just want to perform each addition. Okay, so we'll begin with 29 plus 30. And basically what we want to do is stack these numbers on top of each other and make sure that they're lined up by place value. So 29 plus 30. Notice how it's lined up where the digits in the ones place or the ones column are on top of each other, and the digits in the tens place of the tens column are stacked up on top of each other. So now we want to just add the digits in the ones column, and we're going to work our way to the left after that. So 9 plus 0 is 9. Just go ahead and put the result directly below. And then as we go to the left, next we're going to have 2 plus 3, that's 5. put the result directly below, and we have an answer of 59. Okay, next let's look at 717 plus 182. So again, we're going to stack these numbers up on top of each other, make sure they're lined up by place value. So we're going to start with the digits in the ones column. So 7 plus 2 is 9. And we're going to work our way to the left. 1 plus 8 is 9 as well. And then 7 plus 1 is 8. So we end up with 899 as our answer. So lastly, we have 5060 plus 129. And whenever we have numbers that we're adding, and we have one number with more digits than the other, we're going to typically take the number with the most amount of digits and put that on top. So I'm going to take 5060 and put that on top of 129. And again, make sure you line it up by place value. We're going to start with the rightmost column, or the ones column. 0 plus 9 is 9. Then we'll do the tens column. 6 plus 2 is 8. Then we'll do the hundreds column. 0 plus 1 is 1. And then we have the thousands column, which just has a 5 here. Nothing down here, so we can just basically bring this number down, or say 5 plus 0 equals 5. So we end up with 5,189 as the answer. Hello and welcome to Pre-Algebra Test Section 2 on vertical addition. So for the problems we're going to look at today, we just want to perform each addition. Okay, for the first problem, we have 593 plus 715. And again, to work these problems, we start out by stacking the numbers on top of each other and by place value. So we'll take 593 and stack that on top of 715. And notice how everything is lined up. Your digits in the ones place are lined up on top of each other. Your digits in the tens place are lined up on top of each other. And your digits in the hundreds place are lined up on top of each other. So now we start our addition by looking at the digits in the rightmost column, or the ones column. So we have 3 plus 5, that's 8. We write the answer directly below. Now we work our way to the left. So we're going into the tens column. Now we have 9 plus 1, that's 10. Now, like we talked about in the lesson, if your answer is larger than 9, you're going to use a process called carrying. So we think about 10, we take the rightmost digit of this number, and we put it in the answer column. So the 0 goes there. Then we take the leftmost digit of this number, which is a 1, and we carry it into the next column to be included with the addition. So now we move to the next column, and we have this 1 plus 5, that's 6, then plus 7, that's 13. Now normally you'd have to put a 3 down and carry the 1, but there's no more numbers over here, so you can just write 13, right? Because if you carried the 1 into the next column, it would just come down. There's nothing to add it to. So our answer here is going to be 1,308. Okay, let's continue with 2,950 plus 3,087. So 2,950 plus 3,087. Again, notice how your numbers are lined up by place value. So we're going to begin in the rightmost column and work our way to the left. So 0 plus 7 is 7. 5 plus 8 is 13. So I'm going to put a 3 down, the rightmost digit, and I'm going to carry a 1, the leftmost digit. Then I'm going to continue with my addition. 1 plus 9 is 10. So I'm going to put a 0 down, which is the rightmost number, and then I'm going to carry the 1, which is the leftmost number. So then we have 1 plus 2, that's 3. 3 plus 3 is 6. We end up with 6,037 as our answer. Okay, for the final problem, we have 6,591 plus 97,563. So again, we're going to stack these numbers on top of each other and align them by place value. Now, these two numbers have a different amount of digits in them. Typically, what you're going to see is when a number has more digits, you're going to put that one on top. You don't have to do it that way, but generally that's what we do. So we're going to take 97,563 and put that on top of 6,591. Now we're ready to add. So we start in the rightmost column. So we have 3 plus 1, that's 4. We're going to work our way to the left. 6 plus 9 is 15. Put a 5 down, carry a 1. Right? If you think about 15, the rightmost digit is a 5. That goes in the answer column. The left digit is a 1 that gets carried into the next column. Now we have 1 plus 5, that's 6, plus 5, that's 11. Put a 1 down, okay, the rightmost digit, and carry a 1. So now we have 1 plus 7, that's 8. Then 8 plus 6 is 14. So we're going to put the 4 down, the rightmost digit, and we're going to carry a 1. Carry a 1 over here. So 1 plus 9 is 10. And because there's no more numbers here, I can just write 10. So we end up with 104,154 as our answer. Hello and welcome to Pre-Algebra Test Section 3 on vertical addition. So for the problems we're going to look at today, we just want to perform each addition. And let's start out with 598,753 plus 6,322,195. Now, as I keep repeating, generally what you're going to do is you're going to start out by putting this number, the 6,322,195, on top because it has more digits. That's just a common practice. If you wanted to put this number, the 598,753 on top, you can do that. You will get the same answer. So, again, we want to stack the numbers on top of each other, line them up by place value. So we're going to have 6,322,195. I'm going to put that on top. I'm going to put 598,753 on the bottom. And again, I can't stress this enough. Notice how I line up all the numbers in the ones place, all the numbers in the tens place, all the numbers in the hundreds place, so on and so forth moving down. Now, when we start our addition, we start in the ones column, and we're going to add 5 plus 3. We know the result is 8, so we put it directly below into our answer column. Move to the left, we have 9 plus 5. Now 9 plus 5 is 14. That result is too big to put in the tens column for the answer. So we use a process called carrying. With carrying, you think about the number 14. The right part, or the 4, is going to go into the answer column. So I'm going to put the 4 there. The 1, or the left part of the number, is going to get carried into the next column to be included with that column's addition. So now we're going to have 1 plus 1, that's 2. Then 2 plus 7 is 9. Next column, we have 2 plus 8, that's 10. So again, we're going to split the number up, right? We're using the carrying process. The right part of the number, the 0, goes into the answer column. And the 1, the left part of the number, gets carried into the next column. So now we're going to include that in our addition. 1 plus 2 is 3. 3 plus 9 is 12. Again, break 12 up. The right part of the number is the 2. The left part of the number is the 1. So you're going to carry that into the next column. Then we have 1 plus 3, that's 4. 4 plus 5 is 9. And then finally I have 6. I'm not adding anything to that. So bring that number down. And we get 6,920,948 as our answer. All right, next let's look at this 655,999 plus 9,875,822. So we're going to stack these numbers on top of each other and line them up by place value. So again, I like to take the number with more digits and put that on top. 9,875,822. I'll take the number with fewer digits, put that on the bottom, 655,999. Again, if you switch this, put this on top and this on the bottom, you get the same answer. Does not matter whatsoever. So let's start our addition in the ones column. So we'll do 2 plus 9, and that's 11. So immediately we have to carry. Remember, put the rightmost digit, which is 1, into the answer column, and carry the leftmost digit into the next column. So in this case, each digit is a 1, so we just put a 1 in the answer column, and we carry a 1. Now we have 1 plus 2, that's 3. 3 plus 9 is 12. So I'm going to put a 2 down, and I'm going to carry a 1 into the next column. Now I have 1 plus 8, that's 9, and 9 plus 9 is 18. So I'm going to put an 8 down, and I'm going to carry a 1 into the next column. 1 plus 5 is 6, 6 plus 5 is 11. So I'm going to put a 1 down, and I'm going to carry a 1 into the next column. Now I have 1 plus 7, that's 8. 8 plus 5 is 13. So I'm going to put a 3 down, and I'm going to carry a 1. Okay, I'm going to carry a 1 into the next column. Now I have 1 plus 8, that's 9, and 9 plus 6 is 15. So I'm going to put a 5 down, and I'm going to carry a 1 into the next column. So lastly, we have 1 plus 9, and that's 10. So when I have no more numbers over here, I don't have to use any kind of carrying. I can just write that number into the answer. So we end up with 10,531,821 as our answer. Hello and welcome to Pre-Algebra Test Section 4 on vertical addition. So for the problems we're going to look at today, we would just want to perform each addition. And so we begin with 199,573 plus 996,522. So we want to start by stacking these numbers on top of each other, but we got to make sure that they're lined up by place value. So we have 199,573. We have 996,522. And just notice how we have our place value for each number aligned. So in other words, the 3 here, which is in the ones place for 199,573, sits directly on top of the 2, which is in the ones place for this number 996,522. And as we move to the left, we basically do the same thing for the tens, the hundreds, the thousands, the 10,000s, and the 100,000s. Okay, so now we're ready to add. And to add, we basically start at the rightmost column, or the ones column, and we just sum the digits. So 3 plus 2 is 5. So I just put that answer directly below, and I move to the left now. 7 plus 2 is 9. Put the answer directly below. And then we get 5 plus 5, that's 10. So whenever we have an answer that's larger than 9, we have to do something called carrying. So if we think about the number 10, we basically just split it up into the right part and the left part. So the right part of this number, 0, is going to go into the answer. The left part is going to get carried into the next column. So we're going to carry this 1 over here, and we're just going to include it in our addition now. So we have 1 plus 9, that's 10, and then 10 plus 6 is 16. So we're going to do the same thing. We're going to take the right part of that number, which is 6, put it in the answer, and then we're going to carry the 1 into the next column. Include it with the addition. So 1 plus 9 is 10, 10 plus 9 is 19. Doing the same thing. We're going to put a 9 down, which is the right part of the number, and then we're going to carry the left part, which is a 1, into the next column. So now I can add in this column. 1 plus 1 is 2. 2 plus 9 is 11. So because there's no numbers over here, I could just go ahead and write the 11 like that, put a comma, and we're done. So our answer is 1,196,095. Okay, for the last problem, we have 39 plus 715 plus 1,037. So we're adding 3 numbers here, but basically the procedure is the same. We're just going to stack the numbers on top of each other and line them up by place value. So you take the number with the largest amount of digits in it, and you put that one on top. You don't have to, but it's generally what we're going to do. So this number, 1,037, has 4 digits. Okay, it has 4 digits, so I put that one on top. 715 has 3 digits, so I'll put that one in the middle. And 39 has 2 digits, so I'll put that one on the bottom. And again, if you change the order of this, if you wanted to put 715 on top and 1,037 on the bottom and 39 in the middle, you're going to get the same answer. This is just generally how we do it. Okay, so we're starting in the ones column here, and we're just summing. So 7 plus 5 is 12. 12 plus 9 is 21. So because I can't fit 21 here, I use the carrying process. Take the right part of 21, which is a 1, put it in the answer, carry the 2 to the next column. Now we add. 2 plus 3 is 5. 5 plus 1 is 6. 6 plus 3 is 9. Then we go to the next column. 0 plus 7 is 7. And then the final column, we just have a 1, and that can basically just come down, right? So we end up with 1,791 as our answer. Hello, and welcome to Pre-Algebra Test Section 5 on vertical addition. So for these problems, we want to perform each addition, and we're going to start out with 315 plus 975 plus 10,341 plus 31,393. So when we add more than 2 numbers together, the process is still the same. We want to stack these numbers on top of each other and line them up by place value. So typically what we do is we take the numbers with the larger amount of digits in them. So in other words, this number has 5 digits, this number has 5 digits, this number has 3 digits, and this number has 3 digits. So you want to take the ones with the larger amount of digits in them and put those on the top. You don't have to, but that's generally what we do. So 10,341 can go on the top. Then 31,393 can go below that. Then let's take 975 and put that below that. And then we'll finish up with 315. And again, if I change the order here, it's not going to matter. I can put 315 on top. I can put 975 on top. It doesn't really matter. It just, in my opinion, just makes it easier if you put the larger numbers or the numbers with more digits in them on the top. Okay, so let's do some addition now. So we start by looking at the numbers in the rightmost column. Okay, so in the rightmost column or the ones column, and we're just going to add those. So 1 plus 3 is 4, 4 plus 5 is 9, and then 9 plus 5 is 14. So I can't fit a 14 there, so what we need to do is use a process called carrying. And when you carry, you take the rightmost part of that number, or the rightmost digit of that number, 14, and you put it in the answer. So I'm going to put a 4 there, and then I'm going to carry the left part into the next column. So the 1 goes there. Now, I just do my addition in the next column, and I include this 1. So 1 plus 4 is 5, 5 plus 9 is 14, 14 plus 7 is 21, and then 21 plus 1 is 22. So again, I need to carry. I'll put the rightmost part of that number, which is a 2, in the answer, and then I'll carry a 2. We continue. 2 plus 3 is 5, 5 plus 3 is 8, 8 plus 9 is 17, and then 17 plus 3 is 20. So I put the rightmost part of 20, which is a 0, down in the answer, and then carry a 2. Now I have 2 plus 0, that's 2, and then 2 plus 1 is 3. And then finally I have 1 plus 3, which is 4. So our answer is 43,024. Final problem, we have 513,212 plus 9,375,158 plus 126,393,591. So again, we're going to stack these numbers on top of each other. This number here, 126,393,591, has the largest amount of digits in it. So I'm going to put that on top. So 126,393,591. Then I'm going to take this number right here. I'll put that in the middle. The 9,375,158. And then on the bottom, I'm going to put 513,212. Okay, so now we're just going to add, and we're going to start in the ones column. So 1 plus 8 is 9, 9 plus 2 is 11. And again, we need a carry. So I'm going to put a 1 down, and I'm going to carry a 1. Put the rightmost number down in the answer column, then carry the leftmost number into the next column. So 1 plus 9 now is 10. 10 plus 5 is 15. 15 plus 1 is 16. Put a 6 down, the rightmost part of that number. Carry the 1, the leftmost part. Now we continue. 1 plus 5 is 6. 6 plus 1 is 7. 7 plus 2 is 9. Go to the next column. 3 plus 5 is 8. 8 plus 3 is 11. So put a 1 down, carry a 1. Now we continue. 1 plus 9 is 10. 10 plus 7 is 17. 17 plus 1 is 18. So we're going to put an 8 down. We're going to carry a 1. 1 plus 3 is 4. 4 plus 3 is 7. 7 plus 5 is 12. So we'll put a 2 down, carry a 1. 1 plus 6 is 7. 7 plus 9 is 16. So we're going to put a 6 down and carry a 1. 1 plus 2 is 3. And then this 1 can just go down. And you just bring this down. So we end up with 136,281,961 as our answer. Hello and welcome to Pre-Algebra Practice Set number 8. And in this video, we're going to look at some additional practice problems for the lesson that we did on subtracting whole numbers using a number line. So for the problems we're going to look at today, we want to perform each subtraction using a number line, then label the parts of the subtraction problem. So let's take a look at the first one. Okay, we're going to start out with 11 minus 3. So 11 minus 3. So to do this on a number line, we're going to start at the leftmost number of the subtraction problem, otherwise known as the menu end. So we're going to find that on the number line. So here's 11. And basically what we want to do is we want to move to the left by the number of units being subtracted away. So if we have 11 minus 3, we're subtracting away 3. So we're just going to go 3 units to the left on the number line. So that's going to be 1, 2, and 3. So that puts us at 8. And so that's the answer for our problem. So 11 minus 3 is equal to 8. Of course, we all know that already. Let's go ahead and label the parts of the subtraction problem now. So we have 11 minus 3 equals 8. So 11 is known as the menu end. The menu end. That's the whole amount or the amount that you start with. 3 is known as the subtrahend. And that's the amount that's being taken away. We're taking 3 away from 11. And then lastly, 8, which is the result of the subtraction operation, or you could say the result of 3 being taken away from 11, it's called the difference. Okay, so again, 11 is the minuend, 3 is the subtrahend, and 8 is the difference. Okay, for the next problem, we have 6 minus 4. And of course, we start the same way. We look at the left number of the subtraction problem. And in this case, that's 6. Find that on our number line. So that's right here. And then we're subtracting away 4. So we're just going to go 4 units to the left in the number line. So starting at 6, we're going 4 units to the left. That's 1, 2, 3, and 4. And we end up at 2. So 6 minus 4 equals 2. And to label the parts of the subtraction problem, 6 minus 4 equals 2. 6 is the minuend. Again, that's the whole amount or the amount we're starting with. Then 4 is the subtrahend. That's the amount we're subtracting away. And then 2, which is the result of 6 minus 4, is the difference. Okay, now we have 15 minus 9. So again, we're going to look for 15 on the number line. That's our leftmost number for the subtraction problem, and that's going to be right there. Now we're subtracting away 9, so that means we're going 9 units to the left on the number line. So count them out. 1, 2, 3, 4, 5, 6, 7, 8, and then finally 9. So that puts us at 6. And so that's going to be our answer. So 15 minus 9 is 6. And of course, we already know that. So 15 minus 9 equals 6. So let's go ahead and label this guy. So 15 is the minuend. Okay, again, that's the whole amount we're starting with. 9 is the subtrahend. That's the amount we're taking away, right? We're subtracting 9 away from 15. And then 6 is the difference. Okay, 6 is the difference. It's a result of 15 minus 9. Okay, last problem. We have 4 minus 3. And obviously the answer to that is 1. We're going to do it on the number line. So 4, the leftmost number, is going to be right here on the number line. And we're subtracting away 3. So let's go 3 units to the left on our number line. So that's going to be 1, 2, 3 units to the left to put us at 1. And again, of course, we know that 4 minus 3 is 1. We just want to do it on a number line. So 4 minus 3 equals 1. Let's label this one last time. The leftmost number here, this 4, is the whole amount that we're starting with. This is the minuend. This 3 here is the amount we're subtracting away, or the amount we're taking away. That's our subtrahend. And then lastly, 1 is going to be our difference. It's the result of 4 minus 3. Hello and welcome to Pre-Algebra Test Section 1 on subtracting whole numbers using a number line. So today we want to perform each subtraction using a number line, then label the parts of the subtraction problem. So we're going to begin with 9 minus 2. So the way we subtract on a number line is we start out at the leftmost number of the subtraction problem, and we find that on the number line. So we have 9 as the leftmost number of the subtraction problem, and on the number line, that guy is right there. Now, we're subtracting away 2. So when we subtract away 2, we move 2 units to the left on the number line. So we're just going to go 1, 2 units to the left on the number line, and we end up at 7. So that will be our answer for this problem. 9 minus 2 equals 7. Now, it also asks us to label the parts of the subtraction problem. So a subtraction problem has 3 parts. The first part is called the minuend. So this 9 right here is the minuend. And basically that represents the whole amount or the amount we're starting with. Then 2 is known as the subtrahend. Okay, it's known as the subtrahend. The subtrahend is the amount that we're taking away. So we're taking 2 away from 9. So that's why 9 is the minuend. That's the whole amount. 2 is the subtrahend. That's the amount we're taking away. Then the result of 9 minus 2 is 7. This is known as the difference. Okay, so 7 is the difference. For our final problem, we have 7 minus 6. So we start out on the number line at 7, the leftmost number of the subtraction problem. And then, since we're subtracting away 6, we're just going to move 6 units to the left. So we're going to go 1, 2, 3, 4, 5, 6 units to the left, and end up at 1. Okay, we end up at 1. So 7 minus 6 equals 1. And again, to label the parts of the subtraction problem, 7 is the amount we start out with. So this is your minuend. 6 is the amount that we're subtracting away. That's what we're taking away from 7. So this is the subtrahend. And then 1 is the result of the subtraction operation. So we have 7 minus 6, that gives us 1. So 1 is known as the difference. Hello and welcome to Pre-Algebra Test Section 2 on subtracting whole numbers using a number line. So for the problems today, we want to perform each subtraction using a number line, then label the parts of the subtraction problem. So we're going to begin with 11 minus 5. So we start out at the leftmost number of the subtraction problem, and we find that guy on the number line. And then if we're subtracting away 5, it means we move to the left 5 units on the number line. So we're going to go 1, 2, 3, 4, and 5 units to the left to end up at 6. So that will be our answer for 11 minus 5. That equals 6. So now we need to label the parts of this subtraction problem. So you have 3 parts to a subtraction problem. You have the minuend, you have the subtrahend, and you have the difference. So the minuend is going to be this number here on the left. This is the minuend. And that's basically the amount we start with. So you can think of it as, let's say I start out with $11 and I spend $5 on a sandwich and I end up with 6. So 11 would be the amount you start with. That's your minuend. Now 5, the amount you spend or the amount that's taken away, this is called the subtrahend. This is the subtrahend. And then the result that you get from subtracting 11 minus 5 is known as the difference. Okay, the difference. So 6 is the difference. Okay, let's look at another one. We have 6 minus 6 here. So we all know that 6 minus 6 is 0, but we want to do it on a number line, and we're just going to start at the leftmost number here. So we're going to find 6 on the number line, that's right there. And then we're subtracting away 6, so we're just going to move 6 units to the left. So we're going to go 1, 2, 3, 4, 5, and then finally 6 units to the left to end up at 0 on the number line. Okay, so 6 minus 6 equals 0. Now, let's label the parts of the subtraction problem. Now, we have the same number involved in 2 different areas, but we still label them differently. This 6 on the left is the minuend. Minuend. This 6 right here, to the right of the other 6, is the subtrahend. You can just think of this as I start with $6 and I spend $6 and I'm left with $0. So my starting amount was 6, that's the minuend. I'm subtracting away 6, that's the subtrahend. Let me make that D a little bit better. Subtrahend. And then I end up with 0. That's the result of the subtraction operation. This is the difference. Hello and welcome to Pre-Algebra Test Section 3 on subtracting whole numbers using a number line. Okay, so for the problems, we want to perform each subtraction using a number line, then label the parts of the subtraction problem. So we're going to begin with 13 minus 4. So to do 13 minus 4 on the number line, we start out at 13 on the number line. the leftmost number. So here's 13. And then if we're subtracting away 4, that means we're going to move to the left of the number line 4 units. So we'll go 1, 2, 3, 4 units to the left, and end up at 9 on the number line. So 13 minus 4 equals 9. Now let's label the parts of the subtraction problem. The amount here on the left, 13, is known as the minuend. This is the minuend. The 4 right here, the amount that's being subtracted away or taken away, is the subtrahend. The subtrahend. And then the 9 here, which is the result of 13 minus 4, is known as the difference. Okay, now we have 5 minus 2. So again, we start out on the number line at the leftmost number of the subtraction problem. So we're going to start on the number line at 5. And then we're subtracting 2 units away. So that correlates to a 2-unit movement on the number line to the left. So 1, 2 units to the left. And that puts us at 3. And that's going to be the answer to our problem. So 5 minus 2 equals 3. And then to label the parts of the subtraction problem, 5, the amount here on the left, the starting amount, is the minuend. 2, the amount that's being taken away or subtracted away, is the subtrahend. And then 3, which is the result of the subtraction operation here, is the difference. Hello and welcome to Pre-Algebra Test Section 4 on subtracting whole numbers using a number line. Okay, so for the problems we're going to look at today, we want to perform each subtraction using a number line, then label the parts of the subtraction problem. All right, so we begin with 9 minus 5. So to subtract on a number line, you start out on the number line at the leftmost number of the subtraction problem. So we're going to start out on the number line at 9, right? We have 9 minus 5, so we start out at 9. Then, whatever we're subtracting away, we're going to go that many units to the left. So we're subtracting away 5 here. So that means that I'm going to go 5 units to the left on the number line. So that means I'm going to go 1, 2, 3, 4, 5 units to the left and end up at 4. Okay, end up at 4 on the number line. So that tells us that 9 minus 5 equals 4. So now we're also going to label the parts of the subtraction problem here. And there's 3 parts. There's a minuend, a subtrahend, and a difference. So this leftmost number here, this 9, basically you can think of it as the whole amount that you start out with. This is the minuend. This is the minuend. And then what we're subtracting away, or what we're taking away from that whole amount, is 5. That's known as the subtrahend. And then lastly, the result of subtracting 9 minus 5 is 4. This is known as the difference. Okay, now let's look at 13 minus 10. Okay, so the first thing we want to do is find 13 on the number line. That's right here. And then we're subtracting away 10, so we're just going to move 10 units to the left. So we're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 units to the left and end up at 3 on the number line. And so 13 minus 10 is equal to 3. So again, to label this, the 13, the leftmost number, is the minuend. The 10, which is the amount being subtracted away or taken away, is the subtrahend. And then the 3 is the difference. Hello and welcome to Pre-Algebra Test Section 5 on subtracting whole numbers using a number line. So for the problems we're looking at today, we want to perform each subtraction using a number line, then label the parts of the subtraction problem. So we begin with 12 minus 7. And to do 12 minus 7 on a number line, we start out by finding the leftmost number of the subtraction problem, which in this case is 12, on our number line. So that guy is right here. Let's go ahead and highlight that. And basically, whatever we're subtracting away, we're moving that many units to the left on the number line. So since we're subtracting away 7, we're going to go 7 units to the left on the number line. So we're going to go 1, 2, 3, 4, 5, 6, and finally 7 units to the left on the number line. So that's going to put us at 5. And so that's the answer for our subtraction problem. Okay, so we have 12 minus 7 equals 5. And now we just want to label the parts of the subtraction problem. So if we look at 12, that's going to be the minuend. The minuend. That's the left number in the subtraction problem. It's the amount that we're starting out with. And then 7 is the amount we're taking away, or the amount we're subtracting away. This is known as the subtrahend. The subtrahend. Then finally, 5 is a result of the subtraction operation here. That's called the difference. 5 is called the difference. Okay, for the final problem, we want to do 10 minus 6. So we're going to start out by finding 10 on our number line. And that guy's going to be right here. And then since we're subtracting away 6, we're just moving 6 units to the left on the number line. So we're going to go 1, 2, 3, 4, 5, and then finally 6. So this is where we're going to stop, right here at 4. So that tells us that 10 minus 6 is equal to 4. And then again, to label the parts of the subtraction problem, the 10 here, the leftmost part of the subtraction problem, is the minuend. The minuend. The 6 is the subtrahend. The subtrahend. And then lastly, the 4 is the difference. Hello and welcome to Pre-Algebra Practice Set number 9. And in this video, we're going to look at some additional practice problems for the lesson that we did on vertical subtraction. So for the problems today, we just want to perform each subtraction. Okay, we're going to begin today with 67 minus 35. So we start out by stacking the numbers on top of each other and lining them up by place value. But this is different from addition. They have to go in a certain order. So this left number here, remember this is called the minuend. The minuend. This guy has to go on top. He's first. He's the whole amount that you're going to take away from. Then this part right here, the 35, this is called the subtrahend. The subtrahend. That's the amount we're subtracting away, or the amount we're taking away from 67. This has to go on the bottom. Okay, this has to go on the bottom. So notice how we've stacked these numbers up where, again, 67 is on top, 35 is on the bottom, and we've lined up the place values. So all the numbers in the ones place line up, all the numbers in the tens place line up, and if we had more digits in these numbers, we would continue. All the numbers in the hundreds place would have to line up, so on and so forth. Now, we're going to start our subtraction in the rightmost column, or the ones column, and we're going to work our way to the left. So we're just going to do 7 minus 5, and that's 2. Then we're going to do 6 minus 3, and that's 3. So we end up with 32 as the answer. Next, we have 98 minus 21. So again, we're going to stack these numbers on top of each other, line them up by place value, but this leftmost number, 98, has to go on top, and then 21 is going to go on the bottom. And again, we start on the rightmost column and work our way to the left. So 8 minus 1 is 7, then 9 minus 2 is 7 as well. So we end up with 77. Okay, for the next problem, we have 710 minus 459. So 710 goes on top, 459 is going to go on the bottom. And when we start our subtraction problem out, we notice we have a little bit of a problem. So when we do this column, the ones column, we have 0 minus 9. So 0, the number on top, is smaller than 9, the number on the bottom. So when we run into this, we use a little procedure called borrowing. Okay? So what we're going to do is we're going to take 1 away from the digit immediately to the left of it. So 1 minus 1 is 0. And then I'm going to write a 1 in front of this digit 0. So this 0 is now going to become a 10. And all I did was I took 10 from the tens place. If you think about this 1 here, since it's in the tens place, it's really a 10. So I took 10 from the tens place and I just stuck it in the ones place. So now instead of having 0, I have 10 in the ones place. So 10 minus 9 is 1. Then I move to the next column to the left and I have the same problem. 0 minus 5. I can't do that, so I need to borrow. So I'm going to go to my neighbor to the left, take 1 away. 7 minus 1 is 6. And then I'm going to write a 1 in front of this 0. So now I have a 10 there, and then 10 minus 5 would give me 5. And then I go to the next column, 6 minus 4 would give me 2. So I end up with 251 as my answer. Now, I explained to you a way to kind of dig into this and see what's going on in the lesson. And basically what you can do is just write these numbers in expanded notation. So 710 is 700 plus 10. And then I'm just going to put plus. I'm going to put a blank space because there's a 0 in the ones place. So we really don't have anything there. But essentially, I'm just going to put a blank space there. And then 459 is 400 plus 50 plus 9. Now, if you think about just subtracting in these kind of columns here, if you think about just subtracting, what would happen when we try to do nothing minus 9? Well, we can't do that, right? So we have to go and borrow. So I go over here and I borrow 10. Let's just cross this 10 out and put a 0. And let's just send it over here and put 10. Now, I haven't changed the value of the number. I still have 700 plus 10. I've just changed the way that it looks. And obviously, we can't fit a 10 in the ones place when we're writing a number. But for the purposes of what we're doing, we're just temporarily doing that so that we can perform the subtraction in that column. So we're doing 10 minus 9. That would give us 1. But now when I go over to the tens column, I have 0 and I'm trying to take away 50. So I have to borrow again. So I go over to my neighbor, which is the hundreds, and I take 100 away. So this 700 becomes 600, and I send 100 over. And if you look at the number, it's still the same. 600 plus 100 plus 10 is still 710. So now I can do subtraction. 100 minus 50 is 50. And then over here, 600 minus 400 is 200. And if I look at this number here in expanded notation, it's 251, right? 200 plus 50 plus 1. So that's what we're doing when we're borrowing. We're just temporarily rewriting the column so that we can perform the subtraction in that column. Okay, now we have 198,387 minus 126,377. So 198,387 minus 126,377. So we start in the rightmost column. 7 minus 7 is 0. Then we move to the left. 8 minus 7 is 1. 3 minus 3 is 0. 8 minus 6 is 2. 9 minus 2 is 7. And then 1 minus 1 is 0, so I don't need to put anything there. So we end up with 72,010, and let me rewrite that. 72,010 is our answer. Okay, next we have 614 minus 79. So 614 minus 79. So when we start in the rightmost column, the ones column, 4 is smaller than 9, so I'm going to borrow from my neighbor. So what you do is you take 1 away, so 1 minus 1 is 0, and then you write a 1 in front of this digit in the ones column. So now the 4 becomes a 14. Essentially, if you think about the place values here, all I did was I temporarily sent 10, right? This 1 right here, since it's in the tens column, is 10, over to the ones column. So instead of having a 4, I have 14, right? 4 plus 10 is 14. Didn't change the value of the number. 600 plus 14 is still 614. So now when we think about this ones column, I can subtract. 14 minus 9 is 5. Okay, is 5. And when we move to the left, we have the same problem. Now I just have a 0 here, and I'm trying to subtract away 7. So borrow from the neighbor. We take away 1. 6 minus 1 is 5. And we put the 1 in front of this digit. So put a 1 in front of the 0, you end up with a 10. So then 10 minus 7 is 3. And then we can just bring down the 5 here. And we end up with 535 as our answer. And again, just for the last time, just thinking about writing these numbers in expanded notation, 614 is 600 plus 10 plus 4. 79 is 70 plus 9. So what we did here, when we crossed out this 1 originally, we were crossing out this 10 and saying that it's 0, and we were sending that 10 over to the ones column. So this 4 became a 14, right? When I put a 1 in front of that 4, it became a 14. Then I did my subtraction. 14 minus 9 is what? That's 5. Now, when I try to do 0 minus 70, I needed to borrow again. So I borrowed a 1, which is basically a 100, because if you think about a 1 in the hundreds place, that's 100. So over here, I'm borrowing 100. So this becomes 500, and this becomes 100. But when you look at it in the standard form, I just wrote it as 10 because 10 tens would be 100. So 100 minus 70 now is 30. And then this 500 just comes down because I'm not subtracting anything away. And so 500 plus 30 plus 5 is 535. Okay, now we have 703,321 minus 698,977. So 703,321 minus 698,977. So when we begin, we immediately need to borrow. 1 minus 7, I need to borrow. So I go to my neighbor to the left. I take away 1. 2 minus 1 is 1. So now this is a 1, and I put a 1 in front of this digit, and that becomes an 11. So 11 minus 7 is now 4. Okay, we have 4. Now when I try to do 1 minus 7, I need to borrow again. So I go over here. I'm going to take 1 away. 3 minus 1 is 2. So this is now a 2. Put a 1 in front of this digit, it becomes an 11. Now 11 minus 7 is 4. Now when I do 2 minus 9, I need to borrow again. So go over here. This 3 is going to become a 2. Right? Just take away 1 and then put a 1 in front of this digit so it becomes a 12. Now 12 minus 9 is 3. Okay, this is 3. Now moving to the left, 2 minus 8, I need to borrow again. But here's where there's a problem, and I talked to you about this in the lesson. You can't borrow from a 0, right? You can't borrow from a 0. So you actually have to borrow in 2 steps. I got to keep going to the left until I get a non-zero number. So when I go to this 7, I'm going to cross that out and subtract away 1 to get the 6. I'm sending my value over to the column to the right. I can't send it all the way over here. I've got to do it in 2 steps. So this becomes a 6, and I put a 1 in front of this digit, it becomes a 10. Now I can borrow from the 10. You think about this, 2, I'm going to borrow from this 10. 10 minus 1 is 9, so now this is a 9, and I'm going to put a 1 in front of the 2 to make it a 12. So now finally I can do my subtraction in that column. 12 minus 8 is 4. And then moving to the left, 9 minus 9 is 0, and 6 minus 6 is 0. So we end up with 4,344 as our answer. Okay, for the final problem, we have 6 million minus 4,578,125. So 6 million minus 4,578,125. Okay, so when we try to do our subtraction in the rightmost column, the ones column, we see we have 0 minus 5. We need to borrow. But the problem is we don't have anything we can borrow from until we get to this 6. So this leads to a long, tedious process. This 6 I'm going to borrow from. The 6 will become a 5, and I'm going to put a 1 in front of the digit here. But I have to keep doing this basically until I get to the ones place. So I'm going to keep borrowing. So the 10 will become a 9, and this will become a 10. Then this will become a 9, and this will become a 10. Then this will become a 9, and this will become a 10. Then this will become a 9, and this will become a 10. And then finally this will become a 9, and this will become a 10. So we have to do all that work just so that we can start our subtraction problem. And when you get numbers with a lot of trailing zeros like that, that's going to happen to you. So we start with 10 minus 5, and that's 5. And then we have a 9 minus 2, that's 7. Then we have a 9 minus 1, that's 8. Then we have 9 minus 8, that's 1. Then we have 9 minus 7, that's 2. Then we have 9 minus 5, that's 4. And then lastly, we have 5 minus 4, which is 1. So we end up with 1,421,875 as our answer. Hello, and welcome to Pre-Algebra Test Section 1 on vertical subtraction. So for the problems we're going to look at today, we want to perform each subtraction. So we're going to start out by looking at 71 minus 55. So when we do vertical subtraction, we want to stack the numbers on top of each other and make sure they're lined up by place value. So I'm going to put 71 on top. and I'm going to put 55 on the bottom. Now, you have to do it that way. Recall when we did vertical addition, it didn't matter. You could put whatever number on the top and whatever number on the bottom, made no change to the result. Here, it will change the result. So we have to make sure that we put the left number here, or the minuend, on top, and the right number here, or the subtrahend, on the bottom. Now, when we perform our subtraction, we start in the rightmost column, and so we would do 1 minus 5. But there's a problem here. When we have a number in the top that's smaller than the number on the bottom, we need to do a little trick called borrowing. So I'm going to go to my neighbor to the left, and I'm going to borrow 1. So if I subtract 1 away from 7, I will get 6. And then I'm going to write a 1 in front of whatever digit is here. In this case, it's a 1, so this will become an 11. Now, we would take 11 and subtract away 5, and that will give us 6. Now we move to the next column to the left, and now this is a 6. It's no longer a 7 because I borrowed from it. So 6 minus 5 now is 1, and we get an answer of 16. Okay, for the next problem, we have 312 minus 18. So 312 minus 18. Okay, so we're going to start out in the rightmost column, and we have 2 minus 8. So again, we need to borrow in this situation because 2 is smaller than 8. So I go to my neighbor to the left, and I borrow 1, and this becomes 0, and I put a 1 in front of that digit. So now I get a 12 here, and I can do my subtraction. 12 minus 8 is 4. Now going to the left, now I have a problem again because this is now a 0, and 0 minus 1 is going to cause us to borrow. So I need to go over to the left and borrow from my neighbor. So subtract 1 away from 3, and I'll get 2. And I'm going to put 1 in front of this digit to make it a 10. So now 10 minus 1 would give us 9. And then 2 minus, you can think of this as 0, or basically just say I'm just going to bring this 2 down to end up with 294 as my answer. Okay, let's look at the last one. We have 1090 minus 1002. So 1090 minus 1002. Now, when I go to subtract in the right column, I need to borrow, right? Because I'm trying to do 0 minus 2. So I borrow from this 9, subtract away 1 from the 9, and we get 8, and put a 1 in front of this digit right here. So now I have a 10. 10 minus 2 is 8. And I move to the left. 8 minus 0 is 8. 0 minus 0 is 0. And 1 minus 1 is 0. So these two zeros don't add any value to the number. So I can just erase them. I don't need them at all. My answer here is going to be 88. Hello and welcome to Pre-Algebra Test Section 2 on vertical subtraction. So for the problems today, we just want to perform each subtraction. We're going to begin with 572 minus 101. So to do a vertical subtraction, you want to stack the numbers on top of each other and make sure they're lined up by place value. But what's different with vertical subtraction versus vertical addition, the order that you subtract in does matter. So you have to be careful about what you put on the top and what you put on the bottom. So this leftmost number here, this 572, otherwise known as the minuend, is going to go on top. That's what we're starting with. Then we're taking away, or we're subtracting away, this number on the right, this 101. This is known as the subtrahend. So minuend, or 572, is going on top. Subtrahend, or 101, is going on the bottom. Now, again, notice how I've lined up the numbers according to their respective place values. So all the numbers in the ones place are on top of each other. All the numbers in the tens place are on top of each other. All the numbers in the hundreds place are on top of each other, so on and so forth. So we begin by just subtracting in the rightmost column, and we're going to work our way to the left. So 2 minus 1 is 1. Going to the left, 7 minus 0 is 7. And then 5 minus 1 is 4. So very easy problem. We end up with 471 as our answer. Okay, so for the next problem, we have 3001 minus 865. So 3001 minus 865. And notice how, again, I put 3001 on top and 865 on the bottom, and the numbers are lined up by place value. When we begin this problem, we start in the rightmost column, and immediately we know that we have a situation. We have 1 minus 5. So when we run into the situation where the number on top is smaller than the number on the bottom, we use a little procedure called borrowing. And to do that, we look to our neighbor to the left and we try to borrow from that. But because this is 0 and this is 0, we have to go all the way over to this 3 to borrow. And we can't just borrow and go straight back to the 1. We have to go through each number. So what we do when we borrow is we take 1 away. So 3 minus 1 is 2. And then we put a 1 in front of the digit to the right. So this 0 will become a 1. Now we're going to borrow again. So this 10 will become a 9. We put a 1 in front of this digit. This becomes a 10. Then we're going to borrow one more time. This 10 becomes a 9. And we put a 1 in front of this digit. It becomes an 11. So now we can finally perform our subtraction in this right column. We have 11 minus 5, that's 6. And now we just move to the left. So now this is a 9. 9 minus 6 is 3. This is a 9. 9 minus 8 is 1. And this is a 2. But I don't have anything down here, so I can just bring it straight down. And I end up with 2,136 as my answer. Hello and welcome to Pre-Algebra Test Section 3 on vertical subtraction. So for the problems we're going to look at today, we just want to perform each subtraction. Okay, for the first problem, we're going to look at 15,984 minus 14,297. You need to stack the numbers on top of each other and make sure they're lined up by place value. But you have to make sure that you put the leftmost number here, 15,984, on the top. Okay, this is known as your minuend, or basically the amount you're starting with. And you have to make sure that you put 14,297 on the bottom. This is your subtrahend, or the amount that you're subtracting away from the 15,984. So it has to go in this order, otherwise you won't get the right answer. Subtraction is not commutative like addition, where you can just do it however you want. So once we have our subtraction problem set up, we're ready to go. We start out in the rightmost column, the ones column, and we're going to work our way to the left. Now when we start our subtraction, we see that there's a problem right away. We have 4 minus 7. So when the number up top here is smaller than the number on the bottom, we need to use a little trick called borrowing. So I go to my neighbor to the left in the tens column, and I'm going to borrow 1 away from it. So 8 minus 1 is 7. And I'm going to write this 4 as 14. I'm just going to put a 1 in front of it. And just thinking about what I did was, this 8 is really an 80. It's in the tens place. So when I write it as 7, now it's a 70. So where did the 10 units go? Where did the 10 go? Well, it's going right here. I had a 4, and now I wrote it as a 14 by putting a 1 in front of the 4. So I haven't changed the value of the number. I've just temporarily changed what it looked like so that I could do the subtraction. So now if I look in the ones column, I have a 14 minus a 7. I can do that. 14 minus 7 is 7. And then I move to the left. Now I have 7 minus 9. I'm in the same boat that I just was in. So I need to borrow again. So to make this kind of short and sweet, I subtract 1 away from 9. That makes it 8. And then I just put a 1 in front of the 7. That makes it a 17. And basically that's what you do when you borrow. You take 1 away from what you're borrowing from, and you put a 1 in front of the digit that you needed to borrow for. So now we have a 17 here, and we can perform our subtraction. 17 minus 9 is 8. And we move to the left. 8 minus 2 is 6. And we move to the left. 5 minus 4 is 1. And then 1 minus 1 is 0. So we end up with 1,687 as our answer. Okay, for the last problem, we have 13,215 minus 9,087. So again, we want to stack the numbers on top of each other and make sure they're lined up by place value. So 13,215 minus 9,087. Again, 13,215, the minuend goes on top, the leftmost number. 9,087, the subtrahend is going to go on the bottom, right? That's what we're taking away. Okay, so when we start our subtraction, we start in the rightmost column. And again, we notice that we have a problem, 5 minus 7. So we need to borrow. And again, to make this quick, you go to the left number. And the left number here is a 1. You're going to take 1 away. 1 minus 1 is 0. Then you're going to put a 1 in front of the digit that you needed to borrow for. So I needed to borrow for this 5. I put a 1 in front of it. I get a 15. So now we can do our subtraction because we have 15 minus 7. That can be done. 15 minus 7 is 8. Now we move to the column to the left. But again, there's a problem because now I have a 0, and I need to subtract away 8. So I'm going to borrow again. Go to my neighbor to the left, and basically I'm going to take 1 away. 2 minus 1 is 1, and I'm going to put a 1 in front of the digit I needed to borrow for. So I'm going to put a 1 in front of that 0, and it becomes a 10. So now I'm going to do 10 minus 8. 10 minus 8 is 2. Moving to the left, I have 1 minus 0, that's 1. Moving to the left, I have 3 minus 9, so I need to borrow. Go to my neighbor to the left, this 1 will become a 0, right? 1 minus 1 is 0. Put a 1 in front of the digit I needed to borrow for, so the 3 becomes 13, and 13 minus 9 is 4. So we have our answer now. It's 4,128. Hello and welcome to Pre-Algebra Test Section 4 on vertical subtraction. So for the problems today, we just want to perform each subtraction. So we're going to begin today with 313,975 minus 303,989. So we have to stack these numbers up on top of each other, and we have to make sure they're lined up by place value. Now it's important what you put on top and what you put on the bottom. The left number here, the menu end, needs to go on top. So 313,975 is going to go on top. And then the subtrahend, the number on the right here, is going to go on the bottom. 303,989. Now we're ready to subtract. And let me just move this bar down a little bit. So we always start in the rightmost column and work our way to the left. So we would start with 5 minus 9. Well, there's a little problem there because this number right here, this 5, is smaller than the 9. So when this happens, we use a little trick, and that trick is called borrowing. So we go to our neighbor to the left and we borrow. So what we do is we'll cross this 7 out, we'll subtract 1 away from the 7, and we'll make it a 6. And then we'll write a 1 in front of the digit. And essentially, if you think about what's going on here, this 7 is in the tens place. So it really represents 70. If I take 1 away from it and put it as a 6, really now it's 60. Okay, so it's 60 instead of 70. So where did the 10 go? Well, the 10 went over here because instead of having a 5, I now have a 15. So I just took 10 away from here and lent it to the 5 to make it a 15. So I didn't change the value of the number. I'm just temporarily changing what it looks like so that I can perform my subtraction. So now I can subtract in the ones column. I have 15 minus 9. That's going to give me 6. Now we move to the left. We have 6 minus 8, and we have a problem again. We need to borrow. So we're going to do the same thing. We're going to go to the left. We're going to subtract 1 away from that, so 9 will be 8. And then we're going to put a 1 in front of the digit that we needed to borrow for. So this 6 is now a 16. So now we can do our subtraction. 16 minus 8 is 8. And we move to the left. We have 8 minus 9. Again, we need to borrow. So we're looking to the left. This 3 will become a 2, right? I'm subtracting 1 away from it, and I'm putting a 1 in front of the digit that I needed to borrow for. So this 8 is now an 18, and now I can do my subtraction. 18 minus 9 is 9. Okay, moving on, we have a 2 minus 3, and again, we need to borrow. So we're going to take 1 away from 1, that's going to give me 0, and I'm going to put a 1 in front of that digit I needed to borrow for. Now that's going to be a 12. So 12 minus 3 gives me 9. Moving to the left, 0 minus 0 gives me 0. And moving to the left again, 3 minus 3 gives me 0. So what we end up with here, since those zeros don't add any value to the number, 9,986 as our answer. Okay, for the final problem, we have 4,277,680 minus 305,000. Okay, so let's go ahead and set this up in vertical subtraction format. This number right here, the menu end, the leftmost number, the 4,277,680 is going to be on the top, and the subtrahend, the number on the right, the 305,000 is going to be on the bottom. So when we start out subtracting, we look at the rightmost column, and so we have 0 minus 0, that gives us 0. Move to the left, 8 minus 0 gives us 8. Move to the left, 6 minus 0 gives us 6. We'll continue moving to the left. 7 minus 5 gives us 2. 7 minus 0 gives us 7. And then we have 2 minus 3. So again, when this number is smaller than this number, we need to borrow. So I'm going to borrow from this 4. 4 minus 1 gives me 3. and then put a 1 in front of the digit that I needed to borrow 4. So the 2 is now a 12. Again, I put a 1 in front of it. So 12 minus 3 would give us 9. And then I can just bring this 3 down. So we end up with 3,972,680 for our answer. Hello and welcome to Pre-Algebra Test Section 5 on vertical subtraction. So for the problems we're going to look at today, we just want to perform each subtraction. And we're going to start out with 80,773,916 minus 42,874. So for vertical subtraction, we just want to stack the numbers on top of each other and make sure they're lined up by place value. But we have to make sure that we do it in the correct order. So this number on the left, known as the menu end, has to go on top. 80,773,916. This number on the right here has to go on the bottom. This is number on the right, 42,874, known as the subtrahend. So 42,874. And again, make sure that you line this up by place value. Otherwise, if you misalign it, you're not going to get the correct answer. So we always start out our subtraction in the rightmost column, the ones column, and we work our way to the left. So if we start with 6 minus 4, we'll get 2. Next, we'll have 1 minus 7. So when we run into something like that, where the number on top is smaller than the number on the bottom, we need to borrow. So we go to the neighbor next to us to the left, and we subtract away 1 from it. So 9 minus 1 is 8. And then we put a 1 in front of the digit that we needed to borrow 4. So now this 1 is an 11. And we can perform our subtraction in that column. 11 minus 7 is 4. Moving to the left, 8 minus 8 is 0. 3 minus 2 is 1. 7 minus 4 is 3. And then over here we just have blank space. So essentially you can just bring the numbers down. So we'll bring down the 7. Bring down the 0, and bring down the 8, and we'll have 80,731,042 as our answer. Okay, for the next one we have 919,121,426 minus 141,914,627. So 919,121,426 is going to go on top. Again, that's the menu end, the left number in the subtraction problem. And then minus, we have 141,914,627. So that number, the subtrahend, the number on the right, the number that we're taking away from the menu end, is going to go on the bottom. Okay, let me write this a little better. 6, 2, and then 7. Okay, so we're going to start subtracting in the rightmost column. And we want to do 6 minus 7. So again, there's an issue there because 6 is smaller than 7. So we're going to borrow from the tens place. So taking 1 away from 2 gives me 1. And I put a 1 in front of the digit that I need to borrow for. So the 6 is now a 16. So 16 minus 7 is 9. And now I go to the next column. Remember, now I have a 1. 1 minus 2, I need to borrow. So this 4 is going to become a 3. The 1 is going to become an 11. Okay, so 11 minus 2 is now 9. And move to the left, I have a 3 minus 6. Again, I need to borrow. Take 1 away from the 1, I get 0. Put a 1 in front of the 3, I get 13. So 13 minus 6 is 7. Okay, now we have 0 minus 4. Need to borrow again. So take 1 away from the 2, you get 1. Put a 1 in front of the 0, you get 10. 10 minus 4 is 6. We keep moving to the left. 1 minus 1 is 0. We keep moving to the left. 1 minus 9, we need to borrow. So I'm going to take 1 away from 9. I'm going to get to 8, and I'm going to put a 1 in front of this 1 here. So now this is an 11. Okay, this is an 11. So 11 minus 9 gives me 2. Keep moving to the left. 8 minus 1 is 7. And now we have 1 minus 4. So we need to borrow again. So this 9 is going to become an 8, right? Subtract 1 away from the 9, you get 8. Put a 1 in front of the 1, and you get an 11. So now we do 11 minus 4. Okay, 11 minus 4, we're going to get 7. Move to the left, 8 minus 1, we're going to get 7 as well. So we end up with 777,206,799 as our answer. Hello and welcome to Pre-Algebra Practice Set number 10. And in this video, we're going to look at some additional practice problems for the lesson that we did on the properties of multiplication. So for the first few problems, we're going to multiply each and identify the components of the multiplication problem. So we begin with 4 times 3. So the multiplication part's very simple. 4 times 3 is 12. And to identify the parts of the multiplication problem, essentially we have factors, which are numbers that are multiplied together. So 4 and 3 are being multiplied together. Those are factors. And then we have something known as the product. So 12 is the product. It is the result of the multiplication operation. Okay, now we have 9 times 4 times 1. So 9 times 4 is 36. 36 times 1 is still 36. And then to label the parts of the multiplication problem, the numbers being multiplied together are known as the factors. So 9, 4, and 1 are factors. And then 36, which is the result, is the product. Okay, here we have 7 times 5 times 0 times 12. Now, I warned you about problems like this in the lesson. This is basically kind of, you can think of it as a trick question. If you think about the fact that 0 times any number will always give you 0, and all of this is just multiplication, there's no other operations involved, 0 will be the result here. 7 times 5 will give you 35, but then once you multiply 35 times 0, you get 0, and then 0 times anything after that will be 0. So if you have numbers that are being multiplied together, and it's only multiplication involved, and 0 is involved in that, you know the answer is 0. Now to label the parts here, we have the numbers that are being multiplied together, the 7, the 5, the 0, and then the 12. These are the factors. And then the 0 here is the product. It is the result of the multiplication operation. Okay, for the next set of problems, we want to rewrite each using the commutative property. And again, the commutative property just tells us that we can reorder the factors in a multiplication problem, and it's not going to change the result. The product will be the same. So if we start out with 12 times 3, notice how 12 is first, 3 is last. We can change the order here and put 3 first and 12 last, and either way you get the same result. 12 times 3 is 36. 3 times 12 is also 36. Next, think about 9 times 11. Okay, we can reorder this using the commutative property as 11 times 9. Again, same result either way. 9 times 11 is 99. 11 times 9 is also 99. Now we have 2 times 8, and again we can reorder this to 8 times 2. 2 times 8 is 16. 8 times 2 is also 16. Okay, now we want to rewrite each using the associative property. And remember, the associative property tells us that when we're multiplying 3 or more numbers, we can group this multiplication however we want. And when I say group, meaning put parentheses around whatever we want, and it won't change the result. So we're going to begin with 3 times 4 inside of parentheses, then times 2. So essentially, the numbers stay the same. 3 times 4 times 2. And I just switch what I have parentheses around. So in this case, I have parentheses around 3 times 4. In this case, I have parentheses around 4 times 2. With the order of operations, it tells us that we do what's inside of parentheses first. So on the left side here, I would do 3 times 4 first. That would be 12. Then I'd multiply 12 times 2, I'd get 24. On the right, I have 4 times 2 inside of parentheses. So I'd do that first, I would get 8. Then I would multiply 8 times 3, I'd also get 24. So you can see that I changed what I had parentheses around. I changed what numbers I multiplied first. And it did not change the result. I got 24 either way. Here we have 9 times 7 inside of parentheses, then times 1. And we'll use the same 3 numbers, 9 times 7 times 1. We're just going to change what we put parentheses around. So in this case, we'll put parentheses around 7 times 1. And again, if we check this, on the left side, 9 times 7 is 63. We do that first because that's what's inside of parentheses. Then times 1, still 63. Over here on the right, 7 times 1 would be done first because that's what's in parentheses. 7 times 1 is 7. Multiply that by 9, still get 63. Okay, now we have 5 times, and then we have 6 times 3 inside of parentheses. So I'm just going to rewrite this as 5 times 6 times 3. And I'm just going to shift the parentheses to where I have parentheses around 5 times 6 now. And again, you get the same answer either way. On the left, 6 times 3 is done first. That's what's inside of parentheses. 6 times 3 is 18. So we would have 5 times 18. And 5 times 18 is 90. And on the right, I'd do 5 times 6 first. That's what's inside of parentheses there. 5 times 6 is 30. So you'd have 30 times 3, and that's 90. So either way, you get 90 as the result. All right, for our last set of problems, we want to use the distributive property to find each product. So we're going to start out with 9 times the quantity 6 plus 2. And I kind of spent a little bit of time explaining what the distributive property was in the lesson. Essentially, when you normally look at this problem, we do what's inside of parentheses first. We do 6 plus 2, that's 8. So you would have 9 times 8, and that's 72. So the distributive property gives us an alternative way to solve this problem. So we have 9 times this quantity, 6 plus 2. So what I can do is I can distribute the 9 to each number inside of the parentheses. So 9 times 6 plus 9 times 2. 9 times 2. You have to remember to write this addition sign. Very, very important. Now, again, we haven't done the order of operations yet, but we need to multiply before we add. So to make that clear, I'm going to put some parentheses around the multiplication operations that we have so that we can keep those separated from the addition. So 9 times 6 is 54. Then plus 9 times 2, that's 18. If we were to find this sum, let me erase this real quick. If we were to find this sum, we would get 72 as well. So either way, we would get the same answer. Okay, let's look at 3 times the quantity 7 plus 4. So if I kind of think about this the usual way, 7 plus 4 is 11. So this is 3 times 11, and that's 33. And then using the distributive property, again, I can distribute the 3 to each number inside the parentheses. So 3 times 7, and don't forget the addition, plus 3 times 4. 3 times 4. And again, just for our purposes, I'm going to put parentheses around these multiplication operations so that we know we do them first. All right, so 3 times 7 is 21. So that's 21. Then plus 3 times 4, that's 12. And if we find this sum here, we get 33. So either way, we get 33. All right, now we have 12 times the quantity 1 plus 9. So again, kind of 1 plus 9 would be 10. So this would be 12 times 10, and that would be 120. Doing it the other way, using the distributive property, we'd have 12 times 1, 12 times 1, plus 12 times 9, 12 times 9. So again, I'm going to put parentheses around the multiplication operation so we don't get confused on what we're going to do. So 12 times 1 is 12. Then plus 12 times 9 is 108. And we find this sum, and again, we get 120. Okay, let's look at a few with subtraction now. So we have 3 times the quantity 6 minus 5. So again, if I work what's inside of parentheses first, 6 minus 5 is 1. This would give me 3 times 1, or 3. So then using the distributive property, and it's the same as if you're doing it with addition, 3 times the quantity 6 minus 5. I'm going to do 3 times 6, 3 times 6, then minus, okay, minus 3 times 5, 3 times 5. So again, I'm going to put some parentheses around the multiplication operations just so that we don't get confused. And again, I just can't stress this enough. You don't need those. So 3 times 6 is 18. Then minus 3 times 5, that's 15. So if we do 18 minus 15, again, we're going to get 3. Okay, let's look at one final problem. After you do enough of these, it becomes very, very simple. And I can't stress to you enough how important it is to understand how to use this property, because when you get to algebra, you're really going to need it. So we have 5 times the quantity 10 minus 3. So again, if I do this by working inside of parentheses first, 10 minus 3 is 7. We'd have 5 times 7, that's 35. If I use my distributive property, I'll have 5 times 10, 5 times 10, minus 5 times 3, 5 times 3. So again, I'm going to put parentheses around the multiplication operations just because I don't want us to get lost. So 5 times 10 is 50. Then minus 5 times 3, that's 15. And we subtract here and we get 35. Hello and welcome to Pre-Algebra Test Section 1 on Properties of Multiplication. Okay, so for our problems today, we want to multiply each and identify the parts of the multiplication problem. All right, so we're going to begin with 6 times 2. And at this point, we all know that the answer to this is 12. When we go to label the parts of the multiplication problem, we think about there are factors and then there's the product. So factors are numbers that are multiplied together. So the 6 and the 2, those are the factors. Okay, those are the factors. And then the 12 is the result of multiplying 6 and 2. That's called the product. A lot of times you'll hear people say 12 is the product of 6 and 2. Okay, now we want to look at 7 times 2 times 1. So 7 times 2 is 14. And then 14 times 1 is still 14. Because remember, when we multiply a number times 1, it remains unchanged. Now, as far as labeling this multiplication problem, we have 3 factors here, 3 numbers that we're multiplying together. So 7, 2, and 1, those are the factors. And then 14, which is the result of this multiplication, is the product. Okay, here we have 171 times 9 times 0 times 5 times 18. So you might go through and say, I need a calculator to do this. But you actually don't. And the reason is because you have a 0 involved. So you have 0 as a factor. And essentially when you multiply something by 0, you always get 0. So whatever 171 times 9 is, which it happens to be 1,539, when you multiply it by 0, you get 0. Then when you multiply times 5, you get 0. Then you multiply by 18, you get 0. So look out for this type of question on a test. You might have a long string of numbers being multiplied together where 0 is one of the factors. You know the result in the end is going to be 0. Now for labeling the parts here, you have 1, 2, 3, 4, 5 factors. So 171 is a factor, 9 is a factor, 0 is a factor, 5 is a factor, and 18 is a factor. And then 0 is the result. It's your answer. So that's the product. Hello and welcome to Pre-Algebra Test Section 2 on Properties of Multiplication. All right, so for this section, we want to rewrite each using the commutative property. Now this commutative property is a pretty simple one. It just tells us that when we're performing multiplication, we can do it in any order and we won't affect our product. So the end result will be the same. So essentially when you see a problem like this and it tells you to rewrite each using the commutative property, you just switch the order around. So we have 3 times 7 here. Just switch the order and put 7 times 3. 3 times 7 is 21. 7 times 3 is also 21. Either way, you'll get the same result. Here we have 12 times 8. Again, just switch the order around and write it as 8 times 12. 12 times 8 is 96. 8 times 12 is also 96. Next, we look at 6 times 7. Again, all we're doing is just switching the order around. So I'm going to write this as 7 times 6. And either way, you're going to get 42. 6 times 7 is 42. 7 times 6 is also 42. Okay, last one. We have 9 times 5. And again, all we're doing here is just changing the order. So 9 is first in this case. Now it's going to be last. 5 is last. Now it's going to be first. So we'll just write this as 5 times 9. And again, either way, the answer is 45. 9 times 5 is 45. And also 5 times 9 is 45 as well. Hello and welcome to Pre-Algebra Test Section 3 on Properties of Multiplication. So for our problems today, we want to rewrite each using the associative property. When we think about the associative property of multiplication, essentially what it tells us is that if you're multiplying 3 or more numbers, you can group that multiplication however you want, and you will not change the product. Meaning, you can put parentheses around different numbers, you can shift that around. You won't change the result at the end of the day. So if we look at 5 times 2, and notice how that's inside of parentheses here. Then we multiply by 7. Using the associative property, we can rewrite this as 5 times 2 times 7. And we're just going to change what we have parentheses around. Now, that's relevant because the order of operations tells us we do operations inside of parentheses first. So if I look at the left and the right side and I think about kind of performing these operations separately, So on the left, I would do 5 times 2 first. That's what's inside of parentheses. 5 times 2 is 10. So I would have 10 times 7. That equals 70. Now think about on the right. You have 2 times 7 inside of parentheses. 2 times 7 is 14. So you would have 5 times 14. But that's also 70. That's also 70. So even though we put different numbers inside of parentheses, meaning we grouped this multiplication differently, we got the same result. So when you're multiplying the same 3 or more numbers, it doesn't matter what you put the parentheses around, you will always get the same answer. All right, let's look at a few more. So we have 8 times, and then 1 times 3 is inside of parentheses. We'll rewrite this with 8 times 1 inside of parentheses, then times 3. And again, either way you do this, you'll get the same result. On the left, you would do 1 times 3 first. That's what's inside of parentheses. You would get 3. You would then multiply that by 8 to get 24. On the right, you do 8 times 1 first. That's what's in parentheses there. You would get 8, multiply that by 3. Again, you get 24. All right, let's look at 10 times 4. That's inside of parentheses there. Then times 2. So again, rewriting this using the associative property, just change what you have parentheses around. That's all we're doing. So 10 times 4 times 2. And I'm just going to put parentheses around 4 times 2 now. Again, if you check this, on the left, 10 times 4 is 40. Do that first because that's what's in parentheses. Then multiply by 2, you get 80. On the right, 4 times 2 is done first. That's what's inside of parentheses. 4 times 2 is 8. Then multiply that by 10, and you also get 80. All right, so final one. We have 3 times 7 inside of parentheses, then times 5. And again, to rewrite this using the associative property, you have 3 times 7 times 5. Again, we're just going to put parentheses around 7 times 5 now. So we have parentheses around different numbers here. And again, we're going to get the same result. On the left, if I do 3 times 7 first, that's what's in parentheses, I get 21. Then 21 times 5 is 105. 105. On the right, I would do 7 times 5 first. That's what's in parentheses there. So I get 35. So you'd have 3 times 35, and big surprise, that's 105 as well. Hello and welcome to Pre-Algebra Test Section 4 on Properties of Multiplication. All right, so what we want to do here is use the distributive property to find each product. And we're starting out with 6 times the quantity 4 minus 2. So I'm going to do this problem 2 ways. I'm going to do it the way in which we work inside of the parentheses first, and then I'll use the distributive property so that you can see you get the same answer either way. So if we do 4 minus 2 first, because that's what's inside of parentheses, you get 2. So this problem would simplify to 6 times 2, and we know that that is 12. Now, if I use the distributive property, what I can do is I can distribute the 6 to each number inside of the parentheses. So I can say, well, this is 6 times 4, 6 times 4, and then we're going to subtract away 6 times 2, 6 times 2. And what I've been doing, since we haven't covered the order of operations yet, I've just been putting these multiplication operations inside of parentheses so that we know to do them separately. Okay, I just don't want you to get confused. But moving forward, you really don't need them because you need to multiply before you do subtraction. Okay, so with that being said, let's do our operations. 6 times 4 is 24. Then minus 6 times 2, that's 12. We do our subtraction and we get 12. So the same result as we got there. Okay, let's look at 3 times the quantity 7 plus 3. So again, if I do it the normal way where we work inside of parentheses first, 7 plus 3 is 10. So we would have 3 times 10. That gives us 30. If I use my distributive property, I can distribute the 3 to each number inside of parentheses. So we'd have 3 times 7. Then we'd have plus, and we do 3 times 3. 3 times 3. And again, I'm adding these parentheses in just for the sake of keeping these multiplication parts separate from the addition so you don't get lost. All right, so we're going to multiply 3 times 7 first. That's 21. Then we're going to do 3 times 3. That's 9. And when we find the sum here, we get 30. Okay, we get 30. Same as we did up here. Now we have 8 times the quantity 9 plus 4. And let's work inside of parentheses first. 9 plus 4 is 13. And then 8 times 13, okay, 8 times 13 is 104. Okay, so now let's do it using the distributive property. So we'll do 8 times 9. 8 times 9 then plus 8 times 4. 8 times 4. And again, I keep adding these parentheses in here just so that you understand that we're doing our multiplication operation separate, and then we're finding the sum. So we're going to do 8 times 9, that's 72. And we're going to add to that the result of 8 times 4, that's 32. So 72 plus 32 is 104. Again, just like we got up there. Okay, finally we have 10 times the quantity 1 plus 3. So again, if we do 1 plus 3 first, that would give us 4. Then we do 10 times 4, that's 40. If we use our distributive property, we'd multiply 10 times 1, 10 times 1, and then we're going to add to that 10 times 3, 10 times 3. And again, I'm going to put parentheses around 10 times 1, and I'm going to put parentheses around 10 times 3, so that we do these separate from our addition. So 10 times 1 is 10, plus 10 times 3, that's going to give me 30. And so 10 plus 30 is 40, just like we got up here. You can see either way we get the same result. Hello and welcome to Pre-Algebra Test Section 5 on the properties of multiplication. So for the problems we're going to look at, we want to use the distributive property to find each product. We start with 3 times the quantity 5 minus 3. So kind of the first way that we do this is we think about doing what's inside of parentheses first. 5 minus 3 is 2. So we could say 3 times 2 equals 6. So the distributive property gives us an alternative way to do this. Basically, we can distribute this 3 to each number inside of the parentheses. So we would do 3 times 5, 3 times 5, and then we would subtract away 3 times 3, 3 times 3. And what I've been doing, since we haven't learned the order of operations yet, I've been putting some parentheses around the multiplication parts here, just so that we know we do them separately. In the order of operations, we're taught that we multiply before we subtract. So normally when you see this, you're not going to have parentheses around it. You would just know that, okay, I do this multiplication here, and I do this multiplication here, and then I subtract the results. But just to make that completely clear, I'm going to put some parentheses around these multiplications here. So 3 times 5 would give us 15. 3 times 3 would give us 9. And when I find the result of 15 minus 9, I get 6, which is exactly what I got up there. Here we have 10 times the quantity 7 minus 7. So we all know this is going to be 0, hopefully, because 7 minus 7 is 0. And when we multiply a number times 0, we get 0. But let's use the distributive property to show this too. So we'd have 10 times 7, 10 times 7, then minus, again, 10 times 7. And I'm going to put parentheses around my multiplication parts just so we don't get confused. So 10 times 7 is 70, then minus 10 times 7, which is also 70, and 70 minus 70 is also 0. Let's look at 8 times the quantity 5 plus 2. If we worked inside of parentheses first, 5 plus 2 is 7. 8 times 7 is 56. If we use our distributive property, we'd have 8 times 5, 8 times 5, plus 8 times 2, 8 times 2. So again, I'm going to put parentheses around my multiplication parts so that we don't get lost. 8 times 5 is 40, plus 8 times 2, that's 16. We find the result of 40 plus 16, and that's 56, same as it was right there. All right, last problem. We have 11 times the quantity 4 plus 1. So for one last time, let's work inside the parentheses first. 4 plus 1 is 5. So then you'd have 11 times 5, that's 55. And if we do it the other way, if we use the distributive property, we'll multiply 11 times 4, 11 times 4, then plus, we'll have 11 times 1, 11 times 1. So again, I'm going to put parentheses around the multiplication parts, again, just because I don't want us to get lost. Just please keep in mind that we don't normally do that. It's just something I'm doing so that we don't get lost and confused about which operation to perform in which order. So 11 times 4 is 44. Then plus 11 times 1 is 11. And if we find this sum, we get 55. Hello and welcome to Pre-Algebra Practice Set number 11. And in this video, we're going to look at some additional practice problems for the lesson that we did on vertical multiplication. Okay, for the problems we're going to look at today, we just want to find each product. And we are going to begin with an easy one, 532 times 4. And to do this in vertical multiplication format, we stack the numbers on top of each other, meaning we do them vertically. And I typically like to take the number with more digits and put that on top. So 532 will go on the top, and 4 will go on the bottom. And again, we put a multiplication symbol out to the left of the bottom number, and we put a horizontal line underneath the bottom number. Now, if you wanted to switch this up and put 4 on the top and 532 on the bottom, you could do that. Remember, multiplication is commutative. You can do it in any order, and it will not change the result. This is just my preference. Now, when we start multiplying, we take this 4 here, and we multiply it by the rightmost digit of the top number, and we work our way to the left. So we're going to do 4 times 2 to start, 4 times 2, and that's 8. So we write the result in the ones column for the answer, and then we're just working our way to the left. So now we're going to do 4 times 3. 4 times 3 is 12. So when I try to fit a 12 in here, there's a problem. So I put a 2 down, the rightmost digit, and I carry a 1. Okay, I carry a 1. Now, the next thing I'm going to do is I'm going to multiply 4 times 5. This 1 here that I carried is not going to be involved in the multiplication. It's just something I'm going to add to the result of 4 times 5. So 4 times 5 is 20. Then I add 1 to that, and I get 21. And so my answer here is 2,128. All right, let's take a look at another easy one. We have 2,197 times 9. So again, I'm going to stack these numbers on top of each other and line them up by place value. And I'm going to take 2,197 and put that on top because it has more digits in it. So again, we start out with 9 times the rightmost digit of that top number, and we work our way to the left. So 9 times 7 is 63. So I'm going to put a 3 down, because that's what I can fit in the ones column, and I'm going to carry a 6 into the next column. Now this 6 is not going to be involved in any multiplication. It's just going to be added to the result of 9 times 9. So 9 times 9 is 81, and then if I add 6, I get 87. So I'm going to put a 7 down, the rightmost digit of 87, and I'm going to carry an 8 into the next column. Again, this 8, what I carried, is not going to be involved in any multiplication. It's just going to be added to the result of 9 times 1. 9 times 1 is 9, then 9 plus 8 is 17. So put a 7 down and carry a 1. And again, the 1 that I carried is not involved in any multiplication. It's just to be added to the result of 9 times 2. 9 times 2 is 18, plus 1 is now 19. So we end up with 19,773 as our answer. Okay, let's look at one that's a little bit harder. We have 5,062 times 15. So I'm going to put 5,062 on the top, and I'm going to put 15 on the bottom. And now, because we have a multi-digit number in the bottom, we have to remember that we start out at the rightmost digit, and we're going to multiply by every digit in the top number, working right to left. So we start out by multiplying by this rightmost digit, and we work our way to the left. So we're going to do 5 times 2, that's 10. And again, I have to carry there. So I'm going to put a 0 down, and I'm going to carry a 1 into the next column. Next, I'm going to do 5 times 6. 5 times 6 is 30. And then I add to that the 1 that I carried. So 30 plus 1 is 31. So I put a 1 down, and I carry a 3 into the next column. Now I'm going to do 5 times 0. 5 times 0 is 0. And now I'm going to add that 3, and that's going to give me 3. And just working my way to the left. Now I'm going to do 5 times 5. So 5 times 5, and that's 25. And there's nothing else over here, so I can just write the 25 in. Now, I'm not done. This 25,310 is what we call a partial product. We have to add that to the result of 1, okay, 1 times 5,062. But remember, because we moved to the left in this bottom number, we have to move to the left when we start writing our answer for this multiplication. And again, the reason for that, as I explained to you in the lesson, is because this 1 is not a 1. It sits in the tens place, so really it's a 10. Really, I'm saying 10 times 2 is 20. So I would put a 2 here to represent 20, right? If I put the 2, if I didn't do this and I did 1 times 2 like that and just said, okay, well, that's 2 right there, that's technically not right, because this is a 10 times a 2, which is a 20. So to correct for that, we go one place to the left, and we start our 2 right here, so that we can say it's a 20. Okay, and just work your way to the left. Now 1 times 6 is 6, 1 times 0 is 0, 1 times 5 is 5. And again, as I told you in the lesson, if you have a 1 in your bottom number, you can just copy this top number down. You just have to make sure you get the place value correct. I could have just copied 5062 down here, just make sure that you shift it to the left. And again, the reason for that is because when you multiply 1 by a number, you get that number back. Okay, so with that being said, you see that I put my addition operation over here. We're going to add these 2 rows here. So we have 25,310 plus, and because of its position, I could really write a 0 here to make this clear, we have 50,620. Okay, so we're adding those 2 numbers. So 0 plus 0 is 0, 1 plus 2 is 3, 3 plus 6 is 9, 5 plus 0 is 5, and 2 plus 5 is 7. So our answer here is going to be 75,930. Okay, for the next one, we have one that's more tedious. We have 2,460 times 319. So 2,460 times 319. So again, always we want to start with the rightmost digit of the bottom number times the rightmost digit of the top number, and we're just working our way to the left. So we're going to do 9 times 0 to start, that's 0. Then 9 times 6, that's 54. So I'm going to put a 4 down, and I'm going to carry a 5 into the next column. Now I want to do 9 times 4, that's 36, plus 5 is 41. So I'm going to put a 1 down, and I'm going to carry a 4 into the next column. Now I'm going to do 9 times 2, that's 18, then plus 4, that's 22. And because there's no more numbers over here, I can just go ahead and write 22. So the result of that is 22,140. So you got to kind of think about this as 9 times 2,460 gives you this. Okay. Now, the next thing we're doing is we have this 1. Okay, we have this 1 that's in the tens place. So remember, when we move to the left, we've got to move to the left here to start our answer, because that's not a 1, it's a 10. Now, something I just did in the last problem, I told you if you have a 1 here and you're multiplying it, really you can just copy the number. Because as you work right to left, you're going to get 1 times 0, that's 0. You're going to get 1 times 6, that's 6. You're going to get 1 times 4, that's 4. And then 1 times 2 is 2. I could have just copied 2,460 down. As long as I know where to start it, I'm okay. Because really, you think about this as 10 times 2,460, which is 24,600. Let me just put a 0 in there. And you don't have to add that in. It's just something I'm doing so that you see what we really have. What is the true value of that number? Okay, so now we're moving to the left again in the bottom number. And so in my answer, I've got to move to the left again. So I started here last time, so I'm moving to the left. Now I'm going to start my answer in the hundreds place. And again, the reason for that is because this 3 is in the hundreds place. It's really a 300. So I'm going to start with 3 times 0. That is 0. And that goes right here. And if I want to make this completely clear, I can put some zeros here, or I can leave it blank. Doesn't really matter. Okay, now I have 3 times 6, that's 18. So we're going to put an 8 down, and we're going to carry a 1. Now we have 3 times 4, that's 12, plus 1, that's 13. So put a 3 down, carry a 1. Then we have 3 times 2, that's 6, then plus 1 is 7. Okay, so now we're just going to crank out this addition. So we're adding all these zeros together. We know that's just going to give us 0. Then we're adding 4 plus 0 plus 0. That's just going to give us 4. 1 plus 6 plus 0 is going to give us 7. 2 plus 4 is 6. 6 plus 8 is 14. Put a 4 down, carry a 1. 1 plus 2 is 3. 3 plus 2 is 5. 5 plus 3 is 8. And this 7 can just come down. So we end up with 784,740. Okay, for the final problem we're going to look at today, we have 583,002 times 1,050. So whenever you see a long problem like this and you have some zeros involved, you can kind of breathe a sigh of relief because those zeros are going to help us a little bit. When you multiply 0 by something, it's 0, so it's going to save us some time. So 583,002 is what I'm going to write on top. And I'm going to take and write 1050 on the bottom. Okay, so we start out at the rightmost digit of the bottom number, and we multiply it by the rightmost digit of the top number, and we work our way to the left. Now, before you start going 0 times 2, 0 times 0, 0 times anything is 0. So the result of this row is just 0. I don't need to go through and write 6 zeros here. Don't need to do it. Because remember, this is a partial product, and at the end of the day, you're going to be adding this up to the other rows. So this doesn't change the value of what we're going to get at all. We don't need it. So we just leave it there as a 0, just to say, hey, I'm done with this, and I'm going to move on to the next one. Okay? So when we go to this 5, remember, we move to the left to get to that 5. So this 5 is in the tens place. So we got to move to the left here. Okay, so we got to think about this and move to the left. So this is where I'm going to start my answer. So I'm going to have 5 times 2. So 5 times 2 is 10. So I'm going to put a 0 down. I remember where to put it. And I'm going to carry a 1. Now I have 5 times 0. That's 0. Plus 1 is 1. Now I have 5 times 0. That's 0. Now I have 5 times 3. That's going to give me 15. So I'm going to put a 5 down. And I'm going to carry a 1. Next, I have 5 times 8, that's 40. Then plus 1 is 41. So I'm going to put a 1 down, and I'm going to carry a 4. And then lastly, I have 5 times 5, that's 25, plus 4 is 29. Okay, so the next thing we want to do is move to the left again. So we move to the left again, and we start in this hundreds column, and we have a 0 there. So in my answer, when I go to write it down, I've got to start in the hundreds column. So I've got to start right there. But again, we have this 0, and we're going to multiply 0 by 2, then 0, then 0. 0 times anything is 0. So I can just write a 0 here and be done. Just move on to the next number to the left. All right, so I move on to this 1 now, and that's also going to help us because it's a 1. Now, again, I got to do the same thing. Because I'm starting in the thousands place, my answer has to start in the thousands place, so it's going to start right there. Right here in the thousands place. Now, 1 times anything is itself. So I don't have to go through and do this multiplication. I can just copy 583,002 and write it in. I just have to make sure I line it up correctly. The 2 has to start right here, and then work your way to the left. So then you'd have 0, 0, 3, 8, and then 5. Okay, now I want to find the sum. And I know this looks like a cluster field, but basically, you can think of this 0 just coming all the way down. All the way down, okay? And if you wanted to, you could have just written some zeros in here. Okay, I could write zeros in there or here. Whatever you want to do to make you feel more comfortable. It doesn't matter. You get the same answer either way. Then we have zeros here, so that just comes down. Then we have a 1 plus 0 plus 0, that's just a 1. Then we have a 0 plus a 2, that's just a 2. Then we have 5 plus 0, that's 5. 1 plus 0 is 1. 9 plus 3 is 12, so put a 2 down and carry the 1. 1 plus 2 is 3. 3 plus 8 is 11, so put a 1 down and carry the 1. Lastly, 1 plus 5 is 6. So we're going to end up with 612,152,100 as our answer. Hello and welcome to Pre-Algebra Test Section 1 on vertical multiplication. Okay, so for our problems today, we just want to find each product. We're starting out with 510 times 9. So to do this problem, we're going to use vertical multiplication. And we basically stack the numbers on top of each other and line them up by place value. As I taught you in the lesson, I typically take the number with more digits and put that on top, and the number with fewer digits and put that on the bottom. As I keep telling you, you may switch this if you'd like. Okay, so we start out with this number right here, the number on the bottom, and we multiply it by the rightmost digit of the number on top, and we work our way to the left. So we would say 9 times 0, that gives us 0. We just write the answer to that multiplication in the ones column. And then we work our way to the left. Now we have 9 times 1, that's 9. And we're just going to write our answer one place to the left. Then 9 times 5 is 45. And no more numbers to multiply over here. So we just write our answer down, and we get 4,590 as our answer. Next, we have 437 times 3. So 437 times 3. So same thing. I stack the numbers up vertically by place value, and I put the number with more digits on top, the number with fewer digits on the bottom. And again, we start out with this number right here, and we multiply it by the rightmost digit of the top number, and we work our way to the left. So 3 times 7 is 21. Now 21 is too big to fit in the ones place for the answer. So we're going to do our little carrying trick. We're going to put a 1 down, which is the rightmost digit of 21, and we're going to carry that 2, the leftmost digit, into the next column. Now, we're not going to use this 2 in any multiplication. We're not going to do that. This is just going to be added to the result of 3 times 3. So 3 times 3 is 9. Then we add 2, and that's 11. So we put a 1 down, and we carry a 1. Now, again, this 1 here that we carried will not be in any multiplication problem that we're doing. We're just going to add it along to the result of 3 times 4. So 3 times 4 is 12. Then add 1, we get 13. No more numbers over here, so I can just write 13 down. So we get 1,311 as our answer. Okay, for the last one, we have 1,064 times 2. 1,064 times 2. And this is a really easy one. We're just going to start again with 2 times the rightmost digit of this top number. So 2 times 4 would be 8, and we work our way to the left. 2 times 6 is 12, so we need to carry. We'll put a 2 down, carry a 1, and again, this 1 will not be involved in any multiplication. We're going to do 2 times 0, and that's 0, and then we're going to add that 1. Okay, so 2 times 0 is 0, plus 1 is 1. And then we have 2 times 1, that's 2. So we get 2,128 as our answer. Hello, and welcome to Pre-Algebra Test Section 2 on vertical multiplication. So for the problems today, we just want to find each product. We'll begin with 139 times 15. So as I taught you in the lesson, we're going to set this up vertically and by place value. So I take the number with more digits and put that on top, 139, and I put 15 on the bottom. Now, again, as I keep telling you in every video, you can switch that and put 15 on top and 139 on the bottom. Multiplication is commutative, so the order is not going to change it. I just personally find this method a little easier. Okay, so to begin our multiplication, we start with the rightmost digit of the bottom number, and we multiply it by the rightmost digit of the top number. So we would do 5 times 9, that's 45. We can't fit 45 into the ones column of the answer, so we write a 5 down, the rightmost digit, and we carry a 4 into the next column. Now we're working right to left, so next we're going to do 5 times 3, that's 15, and then we add the 4, what we carried over. So 5 times 3 again is 15, plus 4 is 19. So we put a 9 down and we carry a 1. Next we would do 5 times 1, that's 5, and then we would add the 1 that we carried over. So again, 5 times 1 is 5, plus 1 is 6. So basically the result of 5 times 139 is 695. Now, the next thing we're doing is we're moving to the left. Okay, we're moving to the left. And we're going to take this 1 and we're going to multiply it by 139, starting with the 9 and working our way to the left. But what we have to do is we have to start our answer for this multiplication one place over to the left. We're going to start our answer in this tens column. And the reason for that is because this 1 is not a 1. It's a 10 because it's in the tens place. So again, we do that to correct for the fact that this is not a 1, this is a 10. So we'll begin with 1 times 9. And again, 1 times 9 is 9. And we work our way to the left. 1 times 3 is 3. Then 1 times 1 is 1. Now what we're going to do here is we're going to add the two results that we got. Now you see that there's a blank space here. There's nothing here because we started our answer to the left. If you feel more comfortable, you can put a 0 there. Okay, you can put a 0 there. If not, we're just doing addition here, so you can just bring the 5 down if you want. 5 plus 0 will be 5 either way. It doesn't matter. So just bring that 5 down, and then 9 plus 9 is 18. Put an 8 down, carry the 1. 1 plus 6 is 7. 7 plus 3 is 10. Put a 0 down, carry the 1. Then 1 plus 1 is 2. So we end up with 2,085 as our answer. All right, next let's look at 14,275 times 24. So I'm going to write 14,275 on top, and I'm going to write 24 on the bottom. And we start at the rightmost digit of the bottom number being multiplied by the rightmost digit of the top number. And again, we work our way to the left. So 4 times 5 is 20. I'm going to put a 0 down and carry a 2. 4 times 7 is 28. Then I add the 2. That gives me 30. So put a 0 down, carry the 3. 4 times 2 is 8. Then plus 3 is 11. So we're going to put a 1 down and carry a 1. 4 times 4 is 16. Plus 1 is 17. So I'm going to put a 7 down and I'm going to carry a 1. 4 times 1 is 4. Plus 1 is 5. So the result of 4 times this 14,275 is 57,100. Now we're moving to the digit to the left in this bottom number. So we're going to be multiplying this 2 by this number, working right to left. Again, remember, when we do that, we got to start by putting our answer in the tens column. So let me move over here. And again, another way to do that would just be to put a 0 here. You can do that, or you can put an arrow over, whatever you want, as long as your answer starts right here, because this 2 is a 20, it is in the tens place. All right, so now we do 2 times 5, that's 10. So there's going to be a 0 here, carry a 1. 2 times 7 is 14, plus 1 is 15. 5 down, carry a 1. 2 times 2 is 4, plus 1 is 5. 2 times 4 is 8. And then lastly, 2 times 1 is 2. And we're going to find this sum here. 0 plus 0 is 0. 0 plus 0 is 0. 1 plus 5 is 6. 7 plus 5 is 12. So we put a 2 down and carry a 1. 1 plus 5 is 6. Then plus 8 is 14. Put a 4 down and carry a 1. 1 plus 2 is 3. So what do we get? We get 342,600 as our answer. Hello and welcome to Pre-Algebra Test Section 3 on vertical multiplication. All right, so we want to find each product, and we have 116,315 times 472. So I'm going to stack these numbers on top of each other, line them up by place value, and as I tell you in every video, I take the number with more digits and put that on top. So 116,315, I'm going to put that on top. I'm going to put 472 on the bottom. And again, I know you get tired of me saying this, but you can flip the order of that and you will get the same answer. All right, so we start by multiplying. We take the rightmost digit of the bottom number and we multiply it by the rightmost digit of the top number, and then we're going to work our way to the left. So we're going to do 2 times 5, that's 10. So we need a carry there. We're going to put a 0 down. We're going to carry a 1. Now we're going to do 2 times 1. 2 times 1 is 2. Then we add 1, we get 3. Then we do 2 times 3. That's 6. We do 2 times 6, that's 12. So we need a carry. Put a 2 down, carry a 1. Then we do 2 times 1, that's 2. Plus 1 is 3. Then finally 2 times 1 is 2. So we have done 2 times this number, 116,315, and this is our result. Again, this is known as a partial product. Okay, a partial product. Now what we're going to do is we're going to move to the left in the bottom number, and we're going to be multiplying with this 7 here. Now because this 7 is in the tens place, it's really a 70. So when I say 7 times 5 is 35, I'm really saying 70 times 5 is 350. So to compensate for the fact that this is a 7 in the tens place, we slide our answer one space over to the left, and we start in the tens column. Okay. Now you can just start there, and you can put a 0 there if you want. You don't have to. A lot of students will put a 0 there. But really, remember what you're doing. You're going to end up adding this, and adding with 0 doesn't change the result. So I can just leave that blank if I want and just do my multiplication. So we're working right to left. 7 times 5 is 35. So put a 5 down, carry the 3. 7 times 1 is 7, plus 3 is 10. So put a 0 down, carry the 1. 7 times 3 is 21, plus 1 is 22. Put a 2 down, carry a 2. 7 times 6 is 42, plus 2 is 44. Put a 4 down, carry the 4. 7 times 1 is 7, plus 4 is 11. Put a 1 down, carry the 1. Then 7 times 1 is 7, plus 1 is 8. So if we look at what happened here, we basically multiplied 7 times 116,315. But again, really it wasn't a 7 because the 7's in the tens place. So I'm saying, hey, 70 times 116,315 is, and you think about this with a 0 because of the position of the number, 8,142,050. I just tell you that you can leave it off because essentially this is a partial product, so we're going to end up adding, and I can just drag that 0 down, or if I had a 0 here, when we add them together, it's still 0. It's not going to matter. Okay, so continuing, we're going to slide to the left one more time. So now I'm going to be working with this 4 here. The 4 is in the hundreds place. It's basically a 400. So I'm going to slide my answer one more space to the left, and I'm going to start right there in the hundreds place. So we're going to do 4 times 5, again working right to left. 4 times 5 is 20. So that's put a 0 down, carry a 2. 4 times 1 is 4, plus 2 is 6. 4 times 3 is 12, put a 2 down, carry a 1. 4 times 6 is 24, plus 1 is 25. Put a 5 down, carry a 2. 4 times 1 is 4, plus 2 is 6. Then lastly, 4 times 1 is 4. Okay, so now we're going to add. Okay, we're going to take these 3 partial products and add. And again, you could have put zeros in here, but you don't need them because when you add with 0, so 3 plus 0 would still be 3. Or 3 plus 5 plus 0 would still be 8. It doesn't matter if you put those zeros in there. So I'm just going to bring this 0 down. Again, as I just said, 3 plus 5 is 8, and then it can just come down. Then 6 plus 0 plus 0 is 6. 2 plus 2 is 4. 4 plus 6 is 10. Put the 0 down, carry the 1. 1 plus 3 is 4. 4 plus 4 is 8. 8 plus 2 is 10. Put the 0 down, carry the 1. 1 plus 2 is 3. 3 plus 1 is 4. 4 plus 5 is 9. Then we have 8 plus 6, that's 14. Put a 4 down, carry the 1. And lastly, 1 plus 4 is 5. So we end up with 54,900,680 as our answer. Hello and welcome to Pre-Algebra Test Section 4 on vertical multiplication. All right, so we just want to find each product. Okay, so for the only problem we're going to work today, we have 63,755 times 4,006. So we're going to stack these numbers up on top of each other and make sure they're lined up by place value. And again, if you wanted to switch this, you could. I always take the number with more digits and put that on top. I find that personally to be a little easier. Now, what are we going to do? We're going to start out in the rightmost digit of the bottom number, and we're going to multiply it by each digit of the top number working right to left. So in other words, we'd start with 6 times 5 and go that way. So 6 times 5 is 30. I would put a 0 down, and I would carry a 3. Now, as I keep telling you, this 3 has no part of the multiplication process. It's just something we're going to add on after. So we would do 6 times 5. That's your multiplication part. That's 30. And then you would add what you carried. So 30 plus 3 is 33. So put a 3 down and carry a 3. Next, we'd have 6 times 7. That is 42. 42 plus 3 is 45. So put a 5 down, carry a 4. 6 times 3 is 18. 18 plus 4 is 22. Put a 2 down, carry a 2. 6 times 6 is 36. Plus 2 is 38. No more numbers over here to multiply, so we just write 38. So essentially, 6 times 63,755 is 382,530. So that's kind of the first part of this problem. Now, we need to multiply every digit of this number by every digit of this number. Now, we work our way left in this bottom number. So next we come across this 0. Now, the beautiful thing about 0 is that when you multiply it by a number, you get 0 back, no matter what you multiply it by. Now, what I've been telling you is that whenever you move left in your problem, you move left as far as where you start your answer. So that 0 times 5 would start out there. Now, I don't need to go through and do each one because all of them would be 0. So I'm just going to put a single 0 there and move on to the next number to the left, which is also a 0. Also a 0. So that would start out in the hundreds column because that 0 is in the hundreds. So we moved 2 spaces to the left, and I do 0 times 5, and that's 0, and I could stop there because everything else would be 0. And so now I've made it all the way to this 4. Now, this 4 is in the thousands place. So we must start our answer for this 4 times 5 in the thousands place. So I'm going to make sure that's lined up properly. So that's going to start out right here. Okay, I'm going to start out right there. So we do 4 times 5, that's 20. So I'm going to put a 0 down, and I'm going to carry a 2 into the next column over. Next, I do 4 times 5. That's also 20, plus 2 is 22. So put a 2 down, carry a 2. 4 times 7 is 28, plus 2 is 30. Put a 0 down, carry a 3. 4 times 3 is 12, plus 3 is 15. Put a 5 down, carry a 1. 4 times 6 is 24, plus 1 is 25. And no more numbers over here, so I can just write that in. Now, we want to add our results. Okay, we want to add our results. It can be a little tricky. Basically, you just put a plus sign out here and just add the individual columns, and you'll get your result. If it makes you feel more comfortable, you can put zeros in here to kind of fill these voids. Put some zeros in here so that you're not so confused. So we'll put this here, and essentially you can see our addition now. So 0 is going all the way down. This is a 0. 3 plus 0 plus 0 plus 0 is 3. 5 plus 0 plus 0 plus 0 is 5. 2 plus 0 plus 0 plus 0 is 2. 8 plus 0 plus 0 plus 2 is 10. Put a 0 down, carry a 1. 1 plus 3 is 4. Then plus 0 plus 0 plus 0 is 4. And then this 5 can come down, this 5 can come down, and this 2 can come down. And we get our answer of 255,402,530. Hello and welcome to Pre-Algebra Test Section 5 on vertical multiplication. So we just want to find each product. Okay, for the only problem, we have 112,964 times 100,503. So I'm going to put 112,964 on top and 100,503 on the bottom. So as we begin, we take the 3, the rightmost digit of the bottom number, and we multiply it by the 4, the rightmost digit of the top number. 3 times 4 is 12. Put a 2 down and carry the 1. Next, we're going to take 3 and multiply by 6. We're working right to left. So 3 times 6 is 18. Then we add what we carried. Okay, so 3 times 6 is 18 plus 1 is 19. Put a 9 down, carry a 1. 3 times 9 is 27. 27 plus 1 is 28. So I'm going to put an 8 down, and I'm going to carry a 2. Next, I have 3 times 2, that's 6, plus 2 is 8. Then I have 3 times 1, that's 3. And then 3 times 1 again, that's 3. Okay, so I'm done with this one, and I'm moving to the left. Now, normally, when I move to the left, I would say, okay, now because I'm starting in the tens place here, I've got to move to the left when I write my answer. When I multiply 0 times this number, I get 0. 0 times 4 is 0, 0 times 6 is 0, 0 times 9 is 0, 0 times whatever you multiply it by is 0. And because we end up adding these results, I don't have to even put it in there. I can just skip this over. I don't need to do it whatsoever. I can go straight to this 5 here. Only thing I have to realize is that because this 5 is in the hundreds place, I have to move 2 spaces to the left to the hundreds, and that's where I'm going to start my answer. Okay? So when I multiply 5 times 4, I'm going to put the result right here. So 5 times 4 is 20. So I'm going to put a 0 down, and I'm going to carry a 2 into the next column. Now I have 5 times 6. 5 times 6 is 30. 30 plus 2 is 32. Put a 2 down, carry the 3. Now I have 5 times 9. That's 45. 45 plus 3 is 48. Put an 8 down, carry a 4. Now I have 5 times 2. That's 10. Plus 4 is 14. Put a 4 down, carry a 1. 5 times 1 is 5. Plus 1 is 6. And then 5 times 1 is 5. Okay? So one of the things you can do at this point is you can leave these 2 spaces blank because we end up adding, so these numbers could just come straight down. Or you could put some zeros in there if you want to. Put some zeros there, and you'd have 56,482,000. Now, this space to the left is a 0, and this space to the left is a 0. So we can just skip those over. We don't have to do anything with them because, again, 0 times this number is going to be 0. Then when we get over here, 0 times this number is going to be 0. And when you're adding, if I just had put in zeros, let's say I put a 0 in there, what's it going to do? It's not going to affect anything. So we can skip it over completely. So next we look at this 1. And this 1 is in the hundred thousands place. So we're going to start our answer for this in the hundred thousands place. So that's right here. That's right here. That's where we're going to start our answer. Now, another trick you can think about is 1 times anything is just itself. So do I really need to go through and say 1 times 4 is 4, 1 times 6 is 6, 1 times 9 is 9? No. I can just write this number, okay? Just maintain where you're going to start from as far as your place value. So this 4 will start in the 100,000s place. Then this 6 is going to go to the left of that, then the 9, then the 2, then the 1, then the 1. Okay? And if we want to, we can add some zeros in. And now we're ready to add. Okay? So we took something that was pretty tedious and we made it into something that's somewhat simple. So we have 2 plus 0 plus 0, that's 2. 9 plus 0 plus 0, that's 9. 8 plus 0 plus 0, that's 8. 8 plus 2 is 10, plus 0 is still 10. So I'm going to put a 0 down, carry a 1. 1 plus 3 is 4. 4 plus 8 is 12. Then plus 0 would still be 12. Put a 2 down, carry a 1. 1 plus 3 is 4. 4 plus 4 is 8. 8 plus 4 is 12. So put a 2 down, carry a 1. 1 plus 6 is 7. Then plus 6 is 13. Put a 3 down, carry a 1. 1 plus 5 is 6. 6 plus 9 is 15. Put a 5 down, carry a 1. 1 plus 2 is 3. And then this 1 can come down, and this 1 can come down to give us 11,353,220,892. Hello and welcome to Pre-Algebra Practice Set number 12. And in this video, we're going to look at some additional practice problems for our lesson on multiplication with trailing zeros. Okay, so for the problems we're going to look at, we want to just find each product. So we start out with 605 times 1,000. And essentially what I taught you in the lesson was it's really easy to multiply numbers together when there's trailing zeros involved. Trailing zeros, again, are zeros that occur at the end of a number. So in the number 1,000, we have 1, 2, 3 trailing zeros. In the number 605, we don't have any trailing zeros. We have a 0 here, but it's not at the end of the number. Right? We have the 0 and then we have a 5. So this is not a trailing zero. These, because they're at the end of the number, they're not interrupted by a non-zero digit. These are what we call trailing zeros. So these are the trailing zeros. And this right here is just a regular zero. So to multiply 605 by 1,000, we basically multiply the numbers together by cutting off the trailing zeros. Okay? So you would do 605 times just 1. And the result of that is 605. Then when you're done, you just attach the trailing zeros to the end of the number. It's just that simple. So I have 3 trailing zeros, so I put 1, 2, 3 trailing zeros to the end of this number, and I found my product. It's 605,000. Okay, for the next problem, we have 14,000 times 5,000, and this is a perfect example of when this little trick comes in handy. If you look at 14,000, we have 1, 2, 3 trailing zeros. If we look at 5,000, we have 1, 2, 3 trailing zeros as well. So to do this multiplication, I only need to multiply 14 times 5 and then attach 1, 2, 3, 4, 5, 6 trailing zeros to the end. So what's 14 times 5? Let's do that in vertical multiplication format. 5 times 4 is 20. Put a 0 down, carry the 2. 5 times 1 is 5, plus 2 is 7. So 14 times 5 is 70. So I put a 70 there. And then again, I'm going to attach 6 trailing zeros. So 1, 2, 3, 4, 5, 6. Comma, comma, and I end up with 70 million as my result. Okay, what if we did 522 times 19,000? So 522 does not have any trailing zeros in it, but 19,000 has 1, 2, 3. So essentially what I do is I multiply 522 by 19. And once I have the result of that, I can just attach the 3 trailing zeros to this answer. Okay, so I'd start with 9 times 2, that's 18. Put an 8 down, carry a 1. 9 times 2 is again 18. Now plus 1 is 19. Put a 9 down, carry the 1. 9 times 5 is 45. Plus 1 is 46. Now we're moving to the left and we're starting in the tens column. So when we do this 1 times 2, the result has to go in the tens column here. We got to move over to the left. So 1 times 2 is 2. Then 1 times 2 is 2. and 1 times 5 is 5. And again, when you multiply 1 times something, you just get that back. So I could have just wrote 522 in, just noting where I have to start, right? Noting that it had to have the rightmost digit fall in the tens column. Okay, so let's sum. Bring down the 8. 9 plus 2 is 11. Put a 1 down, carry a 1. 1 plus 6 is 7. 7 plus 2 is 9. 4 plus 5 is 9. So we get 9,918. Let's drag this up here. 9,918. And remember, we want to attach 3 zeros to the end of the number. 1, 2, 3. And now we have our product. We get 9,918,000 as the result. Okay, let's look at 906,000 times 13,200,000. So we got a lot of trailing zeros between the numbers. We've got 1, 2, 3 in this number. We've got 1, 2, 3, 4, 5 in this number. So when we multiply, we can just leave those off. So I'm going to multiply 906 times 132. And basically whatever we get, we're going to attach 1, 2, 3, 4, 5, 6, 7, 8. We have 8 trailing zeros that we're going to attach to the end of this answer. So 2 times 6 is 12. Put a 2 down, carry a 1. 2 times 0 is 0, plus 1 is 1. 2 times 9 is 18. So now I need to move to the left because I'm going to multiply, starting with this 3 that's in the tens column. 3 times 6 is 18. Put an 8 down, carry a 1. 3 times 0 is 0, plus 1 is 1. 3 times 9 is 27. Now I need to move to the left again. And I'm going to be multiplying in the hundreds column. And again, if I multiply 1 times something, I just get that back. So I'm going to just do 1 times 906. That's 609 like that, right? Because if I went through 1 times 6 is 6, 1 times 0 is 0, 1 times 9 is 9. 1 times anything is itself. So now we just need to add. So bring this down. 1 plus 8 is 9. 8 plus 1 is 9, plus 6 is 15. Put a 5 down, carry the 1. 1 plus 1 is 2. 2 plus 7 is 9. 9 plus 0 is still 9. 2 plus 9 is 11. So we're going to get 119,592. I'm going to bring this up here. And remember, I found that there were 8 trailing zeros. 1, 2, 3, 4, 5, 6, 7, 8. Remember, this number over here, just in case you get confused, this is not a trailing zero. It does not occur at the end of the number. All right, so 8 trailing zeros. 1, 2, 3, 4, 5, 6, 7, 8. Go ahead and put some commas in. So our answer here is 11,959,200,000,000. Okay, let's look at one final problem. We have 9,000 times 115 times 10,000. So even though we're multiplying 3 numbers together, the procedure is still the same. I have 1, 2, 3 trailing zeros here. I have 1, 2, 3, 4 trailing zeros here. And in this number, there's no trailing zeros. But all I really have to do is multiply 9 times 115 times 1. And then whatever I get for that, I'm just going to attach 1, 2, 3, 4, 5, 6, 7. There are 7 trailing zeros here to the end, and I'll have my product. So we know that when we multiply by 1, we get the same thing. So I can essentially just erase that. I don't even need it. So what's 9 times 115? 115 times 9. 9 times 5 is 45. Put a 5 down, carry the 4. 9 times 1 is 9. Plus 4 is 13. Put a 3 down, carry the 1. 9 times 1 is 9. Plus 1 is 10. So let me kind of erase this. I'm going to drag this up here. 1,035 was the result of this. And I want to put 7 zeros behind that 5. So 1, 2, 3, 4, 5, 6, and then 7. Comma, comma, comma. So we end up with 10,350,000,000. Hello and welcome to Pre-Algebra Test Section 1 on multiplication with trailing zeros. Okay, so we want to find each product. Okay, so for the only problem we're going to look at, we have 60 times 700. So I taught you in a lesson kind of a shortcut to do this. Realize that these numbers have what we call trailing zeros. So these are zeros that are at the end of the numbers. So for 60, you have one trailing zero. For 700, you have two trailing zeros. So between these two factors, we have three trailing zeros. Okay? So to multiply these numbers quickly, what you do is, for each number, you just kind of cut off the trailing zero, and you think about the numbers that would remain. So on the left, you just have a 6. On the right, you just have a 7. So you multiply those numbers. 6 times 7 is 42. And then when you're done, all you need to do is attach to the end of this the total number of trailing zeros between the two factors. So we had 3 trailing zeros, so we put 1, 2, 3 trailing zeros behind 42. And we get our answer for 60 times 700. It's going to be 42,000. Hello and welcome to Pre-Algebra Test Section 2 on multiplication with trailing zeros. Okay, we want to just find each product. And we have just one problem. It's 313 times 15,000. So when you multiply numbers and at least one of them has trailing zeros, you can use a little shortcut. So look at the trailing zeros in the number 15,000. And when I say trailing zeros, I mean zeros that occur at the end of the number. You have 3 of them. So to multiply this more quickly, we can cut these numbers off. Okay? Cut them off and just multiply 313 times 15. So 313 times 15. Whatever we get here, we just attach 3 zeros to the end of it and we'll have our answer. Okay? So 5 times 3 is 15. Put a 5 down, carry the 1. 5 times 1 is 5, plus 1 is 6. 5 times 3 is 15. Now, we're moving to the left in this bottom number. We're starting in this 1 here. And because that's in the tens place, our answer for this multiplication needs to start in the tens place as well. But realize we're doing 1 times everything here. We're doing 1 times 3, then 1 times 1, then 1 times 3. So I can just write 313 starting from the tens, right? I take the 3, then go to the 1. I'm working right to left, then go to the 3, because that would be the result. Okay, then we're going to add, bring this down. So we'd have 5. 6 plus 3 is 9. 5 plus 1 is 6. 1 plus 3 is 4. So 4,695 is what we get for this. Bring that guy up here. 4,695. And all we need to do is attach 3 zeros to the end of this number, and we're done. So our answer for 313 times 15,000 is 4,695,000. Hello and welcome to Pre-Algebra Test Section 3 on multiplication with trailing zeros. Okay, we want to just find each product, and we're only looking at one problem, 17,300 times 12,000. So when we multiply with numbers with trailing zeros, and when I say trailing zeros, I mean zeros at the end of the number. So in this case, 17,300, you have 1, 2 trailing zeros, and for 12,000, you have 1, 2, 3 trailing zeros. So when you work with numbers in multiplication that have trailing zeros, you can kind of cut the trailing zeros off and just think about the numbers that are there. So here you'd have 173. Here you'd have 12, okay? And you can just multiply those numbers together. And once you're done with that, you can just attach the total number of trailing zeros to the result. So we have 1, 2, 3, 4, 5. So we're going to attach 5 trailing zeros to our answer we get here. It's just going to be that simple. So 2 times 3 is 6. 2 times 7 is 14. Put the 4 down, carry the 1. 2 times 1 is 2, plus 1 is 3. Now we're moving left, and we're doing this 1 here. It's in the tens place, so we need to start our answer down here in the tens place. But realize this is a 1. So I'm basically multiplying 1 times 173. So that's really easy. I'm just going to put a 3 here, a 7 here, and a 1 here. Right? 1 times 3 is 3. 1 times 7 is 7. 1 times 1 is 1. Very, very easy. So now we add. Bring down the 6. 4 plus 3 is 7. 3 plus 7 is 10. Put a 0 down, carry the 1. 1 plus 1 is 2. So we get 2,076. I'm going to drag this up here, and I'm going to attach 5 zeros. 1, 2, 3, 4, 5, comma, comma. So we end up with 207,600,000 as our final answer for 17,300 times 12,000. Hello and welcome to Pre-Algebra Test Section 4 on multiplication with trailing zeros. Okay, so we just want to find each product, and we're looking at one single problem here. 105,000 times 100 times 3,000. Now, just because we have three numbers involved doesn't mean we can't use our regular trick for this. Remember, when you're working with numbers that have trailing zeros, and again, trailing zeros mean that there's zeros at the end of the number. So you have 1, 2, 3 here, you have 1, 2 there, and 1, 2, 3 here. If you're doing multiplication with these numbers, there is a shortcut. What you're going to do is you can cut off the trailing zeros. Okay? Cut off the trailing zeros. And think about what numbers would be left. So I'd have 105, I'd have 1, and I'd have 3. So you can multiply these numbers together. 105 times 1 is just 105. Then if we multiply by 3, 3 times 5 is 15. Put a 5 down, carry the 1. 3 times 0 is 0, plus 1 is 1. 3 times 1 is 3. So this is 315. All I need to do, once I have this result, is attach the total number of trailing zeros to the end of this, and I'll be done. So if we count these out, I have 1, 2, 3, 4, 5, 6, 7, 8. So I would write 315, and then behind it, I would put 8 zeros. 1, 2, 3, 4, 5, 6, 7, 8, comma, comma, comma. So what are we going to end up with? This is 31,500,000,000. Hello and welcome to Pre-Algebra Test Section 5 on multiplication with trailing zeros. Okay, so we want to just find each product, and we only have one problem here. We have 12,000 times 1,800 times 200. So pretty easy to multiply with trailing zeros. Again, trailing zeros are zeros that occur at the end of a number. So for 12,000, you have 1, 2, 3. For 1,800, you have 1, 2. And for 200, you have 1, 2. So if I look at the total number between all the factors, I have 1, 2, 3, 4, 5, 6, 7. So 7 trailing zeros between all the factors involved. So the shortcut that we have for multiplying with trailing zeros, basically you just kind of cut them off from each number, and you look at what number would be there if they didn't exist. Okay, and then you just multiply those together. So in this case, you'd have 12 times 18 times 2. Whatever you get for that result, you attach 7 zeros to the end, which is the total number from all the trailing zeros, and then you have your product. Okay? So what is 12? Let's start with 12 times 18, and then we'll multiply by 2. This is what we're doing. 12 times 18 times 2. So 8 times 2 is 16. Put a 6 down, carry a 1. 8 times 1 is 8, plus 1 is 9. Now I'm going to the left, and I'm going to this 1 here. So that means I got to go to the left here. Now I'm multiplying with a 1. 1 times anything is just itself. So the answer would be 12. And you put the 2 there and the 1 there. You basically work right to left. You'd have 1 times 2, that's 2. 1 times 1, that's 1. So now we're going to add. Bring down the 6. 9 plus 2 is 11. Put a 1 down, carry a 1. 1 plus 1 is 2. So I get 216, and now I need to multiply that by 2. 2 times 6 is 12. Put a 2 down, carry a 1. 2 times 1 is 2, plus 1 is 3. 2 times 2 is 4. So the answer for this is 432. Now, what we've done is we've multiplied 12 times 18 times 2. And again, it's 432. 432. All we need to do now, remember we said there were 7 trailing zeros between all the factors. We just attach those zeros to the end of this number now. 1, 2, 3, 4, 5, 6, 7. And we have our answer for 12,000 times 1,800 times 200. And that's going to be 4,320,000,000. Hello and welcome to Pre-Algebra Practice Set number 13. In this video, we're going to look at some additional practice problems for our lesson on the properties of division. Okay, so we're going to start out with something pretty easy. We just want to label the parts of each division problem. So as you recall from the lesson, each division problem is made up of 3 parts. The dividend, or the left part of the division problem, basically the amount that you start with. The next part is called the divisor. That's the amount that we're dividing by. And then the final part is called the quotient. That is the result of your division operation. So the problem we're given is 14 divided by 7 equals 2. So this leftmost number here, 14, is what we're starting with. This is our dividend. Okay, this is our dividend. Next, we're dividing by the number 7. So we're saying how many equal groups of 7 can be made out of the number 14. So this 7 here is what's known as our divisor. Our divisor. Then lastly, the result of dividing 14 by 7 is 2. So 2 is known as our quotient. Okay, now let's look at 27 divided by 9 equals 3. So again, this number all the way on the left is called the dividend. Okay, 27 is the dividend. And again, that's the number we're starting with. That's the number we're going to split up. And in this case, we're dividing by 9. So we're going to split it up into equal groups of 9. So this 9 here, again, that's what we're dividing by. This is our divisor. And then 3 is the result of the division operation. This is the quotient. Okay, next let's look at 60 divided by 12 equals 5. So again, this leftmost number, this 60, is the dividend. The dividend, and that's what we start with. Then we divide by 12. Okay, 12 is going to be the divisor. The divisor. And again, we're saying how many equal groups of 12 can we make out of 60? And then the result of that is 5. So this is your quotient. All right, now we want to practice a few basic division problems. So we want to find each quotient. So we're going to start with 16 divided by 2. Now, a lot of you already know that 16 divided by 2 is 8. But what if you didn't? How would you figure that out? Well, I kind of talked about 2 methods you could use. Actually, there's a third. You could kind of draw out 16 boxes and then separate them into groups of 2 if you wanted to. You'd find that you have 8 groups of 2. You could use subtraction. So you could say 16 minus 2 equals 14. You could say 14 minus 2 equals 12. All I'm doing is subtracting out groups of 2 until I get to 0. 12 minus 2 equals 10. 10 minus 2 equals 8. 8 minus 2 equals 6. 6 minus 2 equals 4. 4 minus 2 equals 2. And 2 minus 2 equals 0. So you're seeing how many groups of 2 did I pull out of the number 16? So you would just count the number of subtraction operations you did. You did 1, 2, 3, 4, 5, 6, 7, 8. So 16 divided by 2 would be 8. Now, both methods that I just mentioned are completely absurd if you're trying to get an answer quickly, right? You're not going to sit there and list all this stuff out. You don't have time for that. So you need to use multiplication. So we know that 16 divided by 2 equals 8. Let's just start with that fact for a second. Now, I taught you in the lesson that the related multiplication is this times this. So 8 times 2 is going to give me this, 16. Now, knowing that, if I didn't know that the answer was 8, I could replace this with a question mark and replace this with a question mark and just use the times tables to get my answer. What times 2 equals 16? Well, all of us pretty much know that off the top of our heads. 8 times 2 equals 16. Even if you didn't, you could kind of, wander around a little bit and say, okay, well, 6 times 2 is 12, 7 times 2 is 14, and finally 8 times 2 equals 16. So once you get to that result, you know that 8 is the answer. All right, what about 12 divided by 4? And I won't bother with going through and doing subtraction. Let's do this using multiplication. So what number times 4 is going to be equal to 12? Okay, what number times 4 is going to give us 12? Well, most of you will know that the answer to that is 3. Right? The answer to that is 3. And if you didn't know that, you could go through and think about multiplying by 4. Well, we got 1 times 4, that's 4. We got 2 times 4, that's 8. And we got 3 times 4, that's 12. And we could stop there. What about 0 divided by 7? Do I need to go through and say, okay, question mark times 7 equals 0? No, I do not. Because I taught you in the lesson that when you take 0 and you divide it by any non-zero number, the result is always 0. And you can check that with multiplication. 0 times 7 equals 0. Yes, that's true. Going backwards, I could check that. But it's not necessary, again, because whenever you divide 0 by a number, let's say I did 0 divided by, I don't know, 1,362,411. Well, the answer is 0. All right, let's look at 7 divided by 0 now. So the one thing that I should draw your attention to is immediately you should say, I cannot have 0 as a divisor in a problem. So when I see that, I'm supposed to write that the answer is undefined. Okay? If you see 0 as a divisor, it's undefined. All right, what about 146 divided by 1? Well, that's another thing I taught you in the lesson. If you divide by 1, you get the number back. So 146 divided by 1 is just 146. And again, thinking about this, how many groups of 1 can I make out of 146? Well, I can make 146 of them. If you sat there and drew out 146 circles and said, well, how many groups of 1 can I make out of this? Again, you get 146. So dividing a number by 1 leaves the number unchanged. All right, now we have 327 divided by 327. And this is another thing that we learned. When we divide a non-zero number by itself, we get 1. Okay, so 327 divided by 327 is 1. Okay, let's look at some problems where we're going to have a remainder. So 13 divided by 2 equals what? Equals what? So when I have something with a remainder, I'm still going to use the same process to kind of figure out my division answer. I'm going to use multiplication, but I have to know that there's an additional step involved. So when I think about going backwards here, question mark times 2 equals 13. Those of us that know our multiplication tables pretty well know that there's no whole number that you can multiply by 2 to get to 13. So what I'd have to do is think about something that's going to get me close, but not go over. Okay? So the number 6 times 2 would give me 12. 6 times 2 would give me 12. That's close to 13, and it doesn't go over. If I add 1 to 6 and go to 7, 7 times 2 is 14. 14 is over 13, so I've gone too far, so I can't use this. So 6 is going to be used as the answer, but the problem is I have something left over. If I take 13, my dividend, and split it up into equal groups of 2, I can only get 6 of them. I'm going to have 1 left over, right? I'm going to have 1 left over. So I say I have a remainder of 1. Now, how do I know that I had 1 left over? Well, it's the difference between this and this, right? 13 minus 12 gives me 1. That's how I figured that out. Now, when you go through and you check a division problem where there's a remainder, you have to do more than normal. You'll multiply this right here, this 6, that's still considered the quotient, by 2. Okay, so you're still doing that part, but when you're done, you have to add your remainder. Okay, you add your remainder, so that's 1. So 6 times 2 is 12, plus 1 gives me 13, which is my dividend. What about 18 divided by 4? Okay, 18 divided by 4. So again, we're going to work backwards. What number times 4 gives me 18? Well, again, if you know your times tables well, you're going to know that there's no whole number that when you multiply it by 4 is going to give you 18. So I'm going to try to get as close as I can without going over. So I know that 4 times 3 is 12. I know that 4 times 4 is 16. And I know that 4 times 5 is 20. 20 is too much. That's over 18. So we have to go with 4 times 4, which is 16. So my result here is going to be 4, but because I've only kind of used 16, I'm going to have 2 left over, right? 18 minus 16 is 2, so I'm going to have a remainder of 2. And let's practice checking this. You're going to take this, that 4, and multiply it by this, also a 4. When we're done, we add our remainder, and that should give us this back. 4 times 4 is 16. 16 plus 2 is 18. That's exactly what we started with. So we have 25 divided by 3. So what are we going to do here? Again, let's work backwards. So if I did this, question mark times 3 equals 25. What's going to get me close? I know there's no whole number times 3 that's going to get me 25, but what's going to get me close? I know that 8 times 3 is 24. I know that 9 times 3 is 27. So I have to use 8 because that's close without going over. So I'm going to put 8 down as the answer, but there's a problem because I'm going to have something left over. 8 times 3 is 24. So if I make 8 equal groups of 3, I haven't used everything from my dividend, right? Because I started out with 25. I've only used up 24. I basically have 1 left over. So the remainder is 1. Again, just subtract. 25 minus 24 is 1. And then if I wanted to check, I'm going to multiply this times this. So 8 times 3. When I'm done with that, I add the remainder. And I should get this back. 8 times 3 again is 24. And we add 1 to that, and we do in fact get 25 as our answer. Hello, and welcome to Pre-Algebra Test Section 1 on the properties of division. Okay, so for the problems we're going to look at today, we want to label each part of the division problem as dividend, divisor, or quotient. So we're going to begin with 20 divided by 2 equals 10. And so basically the leftmost number of your division problem, that 20 there, that's the number you're starting with. That's the number you're going to divide up or split up or cut up, however you want to think about it. That is called your dividend. That is your dividend. Now, the next number, this 2, that's what we're dividing by. So when we think about this division problem, it's 20 divided by 2. How many equal groups of 2 can I make out of the number 20? So the number we're dividing by is known as the divisor. Okay, the divisor. And then finally we have this 10. That is the result of dividing 20 by 2. This is known as the quotient. Okay, so your result is the quotient. All right, next we have 10 divided by 1 equals 10. Again, the left number here, the 10, is the dividend. This is the dividend. We're dividing by 1. 1 is the divisor. The divisor. And then 10 is the result, so that is the quotient. Okay, now we have 0 divided by 5 equals 0. So 0, the leftmost number, is the dividend. The 5 here, what we're dividing by, is the divisor. And then 0, which is the result of the division operation, is the quotient. Okay, now we have 100 divided by 25 equals 4. So this leftmost number, this 100, is the dividend. Then the 25, what we're dividing by, is the divisor. And then 4, which is the result of the division operation, is the quotient. We'll finish up with 300 divided by 10 equals 30. Again, the left number here is the dividend. Then the number 10 here is the divisor. And then 30 is the quotient. Hello and welcome to Pre-Algebra Test Section 2 on the properties of division. So for the problems today, we just want to perform each division. And we're just going to divide some whole numbers here. Going to be very, very simple. We start out with 16 divided by 8. So most of you will know this off the top of your head. And 16 divided by 8 is 2. But what if you don't know that? So I always start by just putting a question mark there and thinking about the related multiplication statement. So this times this, okay? This times this, we know the answer is 2. 2 times 8 would give us 16. So this times this will give us this. Question mark times 8 equals 16. And then most of you know your times tables well enough to say, okay, well, I know that 2 times 8 is 16, so my answer here is 2. If you didn't, you could just kind of fumble around with what times 8. So you could say, okay, well, 1 times 8 is 8. 2 times 8 is, oh yeah, it's 16. So you could do it like that as well. All right, next let's look at 3 divided by 1. So for 3 divided by 1, I don't need to look at any related multiplication statement. When you divide a number by 1, you get the number. So 3 divided by 1 is 3. If I did 568 divided by 1, I'd get 568. If I did 2073 divided by 1, I'd get 2073. Basically, dividing by 1 leaves the number unchanged. So that's how I know 3 divided by 1 equals 3. All right, let's look at one final problem. We have 14 divided by 2. Now, a lot of us know that that's 7. But if you didn't know, again, you could use a related multiplication statement. So we could go backwards. So we'd say question mark times 2 equals 14. And you might not know that that's 7, so you could just kind of fumble around and say, okay, well, I know 5 times 2 is 10. I know 6 times 2 is 12. Oh yeah, 7 times 2 is 14. So again, the answer is going to be 7. Right? 14 divided by 2 is 7. And again, we found that by using the related multiplication statement, that 7 times 2 is 14. Hello and welcome to Pre-Algebra Test Section 3 on the properties of division. So for our problems, we just want to perform each division. And we're going to start out with 0 divided by 17. So when we think about 0 divided by 17, we think about the fact that 0 divided by any non-zero number gives us 0. So this answer will be 0. Next, we're looking at 12 divided by 12. For this one, we think about any non-zero number divided by itself gives us 1. So 12 divided by 12 would give us 1. And of course, this makes sense because we're saying here that I want to take 12 and split it up into equal groups of 12 each. Well, I can only make 1. Okay, let's look at 20 divided by 10 now. And there's no special trick here. A lot of you will know that this is equal to 2. But if you didn't know that, you would use a related multiplication statement to figure it out. So you would say this times this gives me this. Right? We know it's 2. 2 times 10 gives us 20. But again, if we didn't, we'd say question mark times 10 equals 20. Well, just kind of looking at that, knowing the times table for 10, well, yeah, you could kind of see, okay, well, yeah, it would be 2. If you didn't, you could just kind of fumble around. Well, 1 times 10 is 10. 2 times 10 is, oh yeah, 20. So that's how we know that 20 divided by 10 is equal to 2. Okay, what about 15 divided by 6? So 15 divided by 6 equals what? Again, let's use multiplication to figure the answer out. So question mark times 6 equals 15. So can you think of a whole number that multiplies by 6 and gives you 15? I can't. So that means we must have a remainder involved, meaning we can't make a whole number amount where there's equal groups of 6. Right? We can't do it. So what we're going to do is we're going to think about what times 6 would get us close to 15 without getting over 15. So if I think about 1 times 6, that's obviously 6. 2 times 6, that's 12. 3 times 6, that's 18. That's too big. Okay, that's too big. So we have to go with this one. That's 2. So if I have the number 15 and I split it up into 2 equal groups of 6, 2 equal groups of 6, that's 12, right? As we just demonstrated that 2 times 6 was 12. I'm going to have 3 left over, right? Because 15 minus 12 equals 3. This amount right here is my remainder. It's what I couldn't form another group with. So the remainder is 3. Okay, that's what we had left over. And when you want to check your division and there's a remainder involved, you need to do a little bit more work. Usually we can just multiply this number by this and we get this. Here we can't do that because there's a little bit left over. So we multiply this by this, so 2 times 6. When we're done, we add that remainder. So we add that remainder. This should now get us to this. So 2 times 6 is 12. 12 plus 3 is 15. And that makes sense because I had 15 and I split it up into equal groups of 6. I could only do that twice, so I only used 12 out of the 15. And I had 3 left over. So 2 times 6 was 12, and then I add back in the 3 that I had left over, and I get back to 15. Hello and welcome to Pre-Algebra Test Section 4 on the properties of division. So for the problems today, we just want to perform each division. And we're going to start by looking at 9 divided by 0. So think about this kind of carefully. What is 9 divided by 0? If we said 9 divided by 0 equals what times 0 would give us 9? Well, think about it. When I multiply 0 times anything, I get 0. So this number doesn't exist. And so that's why I taught you in the lesson, when you have 0 as a divisor, okay, as a divisor, you put that the division here is undefined. Undefined. All right, so next let's think about 711 divided by 1. And in the lesson, I taught you that when you divide by 1, you leave the dividend unchanged. So this will just be 711. Okay, what about 23 divided by 7? So for something like this, again, you just work backwards using multiplication. So what times 7 would give us 23? Well, using the times tables, there's no whole number that multiplies with 7 and gives you 23. 3 times 7 will give you 21. 4 times 7 will give you 28. You can't use 4 because that's going to be too big, right? 28 is larger than 23. So the best we can do is put 3 here, but that's not the full answer. Again, think about what division is doing. If I take 23 of something and I split it up into equal groups of 7, I would have 3 of those groups using 21 out of the 23. Okay, and again, I got that by just multiplying 7 times 3. That's how I know I'm using 21 out of the 23. The difference between 23 and 21 is 2. That's what's just left over. You can't make that into another group of 7 because you just don't have enough. So that's called the remainder. That's what's left over. It's the remainder. So your answer here would be 3 with a remainder of 2. And again, how you check this is you multiply the quotient, this part here, this 3, times your divisor. 3 times 7 is 21. And then you add your remainder. So plus 2, that gives you 23. It brings you back to what you started with. Hello and welcome to Pre-Algebra Test Section 5 on the properties of division. Okay, for the problems we're going to look at today, we want to perform each division. And we'll begin with 9 divided by 2. So again, to think about these, we use a related multiplication statement. So I don't know what the answer is. So I'm going to take this unknown, just going to put a question mark here, and I'm going to multiply by 2, and I'm going to arrive at 9. So can we think of a whole number that multiplies by 2 and gives us 9? Well, I can't. So that means we must have a remainder involved here. So if I think about kind of multiplying by 2, I know that 3 times 2 is 6, 4 times 2 is 8, 5 times 2 is 10. So it can't be 5 because, again, 5 times 2 is 10. That's too big. That's more than 9. So we're going to have to go with 4 times 2, which is 8. Now think about what this is saying. I start out with 9 of something. Doesn't matter what it is. Let's say I have 9 pennies. And I want to split up or separate the 9 pennies into equal groups of 2. Well, what's going to happen is I can only separate it into 4 equal groups of 2. 4 equal groups of 2 using only 8 out of the 9 pennies. So I have 1 that's left over. That's called by remainder. Okay, I have 1 that's left over. I don't have enough to make another group of 2, so it's just kind of hanging out by itself. So the answer to this problem would be 4 with a remainder of 1. And remember, when we check these problems and they have a remainder, you have to do a little bit more work. Normally, you can just multiply your quotient times your divisor, so 4 times 2, and that will give you your dividend back. Because we have a remainder, that's not the case. I have to add this back in to get to this. And you'll see that 4 times 2 is 8. Then if we add 1, we do in fact get to 9, which was our starting value or our dividend. All right, what about 11,572 divided by 0? So can we start this problem and say, what times 0 equals 11,572? Is that what we would do? Think about it for a second. Do you know of a number that when you multiply it by 0 would give that to you? No, you don't, because when you multiply by 0, you get 0. So for this reason, I told you in the lesson that when you see 0 as a divisor, okay, when you are dividing by 0, you stop. You do not attempt to solve that problem. This is undefined. We do not divide by 0. All right, for the last one, we're going to look at 14,372 divided by 1. And again, I told you in the lesson, when you divide by 1, you leave the number unchanged. So this is just going to be equal to 14,372. Hello and welcome to Pre-Algebra Practice Set number 14. And in this video, we're going to look at some additional practice problems for the lesson that we did on long division. Okay, so let's take a look at 30 divided by 3. So remember how to set this up. You're going to take 30 and put it underneath that long division symbol that we use, and 3 goes out to the left. Now, we have some steps for long division, and I taught you a little trick to remember it. You have divide, which we use dad to remember that. We have multiply. We use mom for that. We have subtract. Okay, subtract. We have sister for that. Then we have bring down. Okay, bring down. And we used brother for that. Then lastly, we have repeat, repeat, or remainder. And we use the family dog Rover for that. Okay, Rover. And just something you can use again to remember the steps. It's divide, multiply, subtract, bring down, and then repeat or remainder. And again, use the family for that. Dad, mom, sister, brother, and then the family dog Rover. Okay, so with that being said, let's start our division. Now, with long division, you're breaking up your division into a series of steps. So you're basically attacking your dividend one digit at a time. You're going to start with the leftmost digit of the dividend, and you're going to ask how many times will the divisor go into the leftmost digit of the dividend. So 3 goes into 3 how many times? Meaning, what is 3 divided by 3? Well, that's easy. Any non-zero number divided by itself is 1, so the answer there would be 1. And again, in the lesson, I taught you about maintaining your place value when you're writing in your answers. So make sure you put that 1 directly over the number that you were working with. So we're working with 3. We put the 1 there, and then we multiply. So 1 times 3 is 3. Again, make sure to line up your answer with what you were working with. Then we want to subtract. 3 minus 3 will give us 0. Then we bring down. So we're always bringing down the digit to the right. So we're bringing down a 0. And this is going to be our number that we're working with now. 0, 0 is the same thing as just 1, 0. So this is just 0 in the end. And then we repeat or remainder. So we're going to repeat if we brought a digit down. If we didn't bring a digit down, meaning we had no more digits left to bring down, we would then stop and say, okay, if it's 0, there's no remainder. If it's not 0, then that's the remainder. So now we would ask the question, how many times does 3 go into 0? Meaning, what is 0 divided by 3? Well, 0 divided by any non-zero number is 0. So that's going to be our answer there. And when you write your answer, again, once I've put something there, all the answers in the future just go to the right. Okay, you just line them up to the right of that first digit that you put down. Now we multiply. 0 times 3 is 0. Then we subtract. 0 minus 0 is 0. And then we bring down, but there's nothing else over here. Okay, nothing else over here. So we get to the step that says repeat or remainder. We don't repeat because there was nothing else to bring down. So we would have a remainder if this wasn't 0. But because this is 0, basically 30 divided by 3 is 10 with no remainder. And we know that's true because these are relatively small numbers. We can kind of check them in our head. We know that 3 times 10 is 30, right? If I had 30 of something, I split it up into equal groups of 3, I would get exactly 10. Okay, let's take a look at 715 divided by 5. Again, your steps will be to divide. I'll just abbreviate these with the first letter. So divide, multiply, subtract, bring down, and then repeat or remainder. And again, dad, mom, sister, brother, and then Rover. So 715 divided by 5. And again, we're just going to start by asking the question, how many times will 5 go into the leftmost digit of that dividend? Again, we're going to attack the dividend one digit at a time. So 5 goes into 7 just once. Okay, just once. Again, just thinking about 7 divided by 5. I have 7 of something. I want to split it into equal groups of 5. I would get 1 with a remainder of 2. Now, when you're doing long division, you don't think about the remainder until the end. So you just put the quotient part. You don't think about the remainder part. So I would put 1 there. And it's important where I put the 1. notice how I put the 1 directly on top of that 7. You got to think about place value when you're using the long division process. Okay, so the 1 goes directly over the 7, which is what we were working with. Then we multiply. 1 times 5 is 5. That 5 is going to go directly underneath that 7 we were working with. And then we're going to subtract. 7 minus 5 is 2. Then we're going to bring down. And we're always bringing down the next digit to the right. So we bring down that 1. And then this R stands for repeat or remainder. So because we brought something down, we're going to just repeat the process and start dividing over. So now we would say, what is 5 into 21? What is 5 into 21? So basically, 21 divided by 5 equals what? What times 5 equals 21? Well, I know that 4 times 5 is 20, and I know 5 times 5 is 25. 25 is too big, so I'd have to go with 4. I'd have to go with 4. And again, I know that that would produce a remainder, but we don't worry about that until the end. So we put the 4 there, and we multiply. 4 times 5 is 20, and I want to put the 20 directly underneath the 21, and then I want to subtract. So 21 minus 20 is 1. Then bring down. Okay, bring down that 5. And then we're going to repeat the process. So 5 goes into 15 how many times? You're basically asking, what is 15 divided by 5? I think all of us know at this point that that is 3. Again, because 3 times 5 is 15. So that is 3. And now we multiply. 3 times 5 is 15. And I'm going to scroll down a little bit. That's 15. We subtract. 15 minus 15 is 0. And then we bring down. But there's nothing else over here to bring down. So we've come to our termination step, where it would say repeat, which we didn't bring anything down, so we're not going to repeat. Or remainder, which in this case we have a 0, so there is no remainder. We get 143. And essentially what this division problem, again, is telling us is that I had 715 of something. Let's say I had 715 boxes. I keep using that as an example. I split it up into equal groups of 5. I got 143 of those groups. And to check this is easy. You just take 143, which was the quotient, and multiply it by 5. 5 times 3 is 15. 5 times 4 is 20, plus 1 is 21. 5 times 1 is 5, plus 2 is 7. So we end up with 715, which is our dividend. All right, let's take a look at one with a remainder. So we have 291 divided by 4. And again, our steps are to divide, multiply, subtract, bring down, and then repeat or remainder. All right, so we would start by asking the question, how many times will 4 go into 2? Right, the leftmost digit of that dividend. 4 goes into 2. You could put a 0 here if you want, because technically if you do 2 divided by 4, you would get 0, remainder 2. So you could put a 0 there, and you could multiply and go, okay, well 0 times 4 is 0. You could subtract and get 2, and then bring down the 9, and then repeat. But I can get the same result if I just didn't put a 0 there, and I just kind of expanded my selection to just say, okay, well it doesn't go into 2. It's going to go into 29 how many times? So that's what we do. We just simply expand the selection when it doesn't go into the first or the second or the third number, so on and so forth. So now we can just ask the question, how many times will 4 go into 29? So 29 divided by 4 equals what? Well, what times 4 equals 29? Well, I know 7 times 4 is 28. 8 times 4 is 32. That's too big. So it's going to have to be 7. Now, what's important is, where am I going to put the 7 at? Am I going to put it over here? No, I'm not. Remember that we should have had a 0 there, but we just made the problem simpler, right? We would have had a 0 there, and then we would end up putting the 7 there. The reason you put the 7 here is because you're lining it up with the ones place of 29. That's the number we were working with. So the 7 is going to go there. Now, the next thing I'm going to do is I'm going to multiply. 7 times 4 is 28. And notice how I line the 28 directly underneath the 29. Then I'm going to subtract. Okay, so 29 minus 28, we all know that's 1. And then I'm going to bring down. So I'm going to bring down this 1. And I'm going to then repeat the process. So now I'm going to ask, how many times will 4 go into 11? So what is 11 divided by 4? Well, what times 4 gives me 11? I know 2 times 4 is 8. 3 times 4 is 12. So 2 is as big as we can go. So I'm going to put a 2 there. and I'm going to multiply. So 2 times 4 is 8, and then I'm going to subtract. 11 minus 8 is 3. And then I'm going to try to bring down, but there's nothing else over here. So then I've come to my last step, which is to repeat, which we didn't bring anything down, so we're not going to repeat, or remainder. And in this case, this is not a 0, so we do in fact have a remainder, an amount that's left over. And a lot of times we'll drag this back up here and put, okay, well, 72 remainder of 3. And again, if you want to check something like this, when you have a remainder involved, it's a little bit of extra work, because essentially what you said was, okay, I took 291 of something, I divided it into equal groups of 4, I found that I had 72 of those groups, and then I had 3 left over, right? I would need 1 more to get an additional group of 4. I don't have it. I just have 3 that are hanging out that are kind of, can't be made into another group of 4. So to check this, we would take 72 and multiply it by 4. This is basically what we used when we made the groups. So 4 times 2 is 8. 4 times 7 is 28. But we're not done because there's a difference here of 3. So the amount that was left over, the remainder, you have to add to that. So 288 plus 3, and 8 plus 3 is 11. 1 plus 8 is 9, bring down the 2. And in fact, you do get back to 291. So you multiply the quotient by the divisor, and then you add your remainder to that result. Okay, let's look at 1,275 divided by 12. So 1,275 divided by 12. So again, the steps are to divide, multiply, subtract, bring down, and then repeat or remainder. So just because we have a 2-digit number over here doesn't change our process. We're still going to ask how many times will the divisor go into the leftmost digit of the dividend. Well, we could put a 0 here, or we could just expand our selection. We're going to expand it to include the 1 and the 2. So basically I'm asking how many times will 12 go into 12 now? And the answer is once, right? If I have 12 of something, I want to make equal groups of 12, I can just do that once. So I'm going to put the 1 directly over the 2, right? If I think about the number 12, where's the 1's place? Well, it's where the 2 is, so that's where the 1 is going to go. And again, you can verify or think about, well, I would have had a 0 here anyway, so that 1 would have been to the right of the 0, so that's where it belongs. Okay, now we're going to multiply. 1 times 12 is 12. And again, line that up. Subtract. 12 minus 12 is 0. Then bring down. So the 7 comes down, and we repeat, right? We repeat. So 12 goes into 7 how many times? Well, it goes in 0 times, right? If I have 7 divided by 12, and think about this just using whole numbers. I have 7 of something. I want to make equal groups of 12. I can't even make 1. I can't do it. So the answer would be 0 with a remainder of 7. Again, we don't think about remainders until the very end here, so we're just going to put a 0 in. Now we multiply. 0 times 12 is 0. We subtract. 7 minus 0 is 7. We bring down. We bring down the 5. And then we repeat. 12 goes into 75 how many times? Well, we don't work with 12 that often. 12 times what would give us 75? That's what we're trying to figure out. So I know that 12 times 5 is 60. I know that 12 times 6 is 72. That's as close as we're going to get, right? Because 12 times 7 is 84. So I would put 6 here, and then I would multiply. 6 times 12 again is 72. Then we're going to subtract. 75 minus 72 is 3. Then we would bring down. But when we look up here, there's nothing else to bring down. So that brings us to our kind of termination step where we say, okay, repeat, which we're not going to do. We didn't bring anything down, or remainder. So this 3 is going to be your remainder. So we get 106 with a remainder of 3. Again, let's check it. So 106 times 12. When we're done, we add the remainder back in to get this dividend. So 2 times 6 is 12. 2 times 0 is 0, plus 1 is 1. 2 times 1 is 2. 1 times 6 is 6. 1 times 0 is 0, and 1 times 1 is 1. Bring down the 2. 1 plus 6 is 7. 2 plus 0 is 2. Bring down the 1. So I get 1,272. And if I add the 3 to that, my remainder, my amount left over, I'm going to get 1,275. All right, let's take a look at one final problem. So we have 72,900 divided by 180. So 72,900, and that's divided by 180. So we've never worked with a divisor that's 3 digits, even in the lesson. So it's no different. Essentially what I'm going to do is I'm just going to expand my selection more. Because I'm going to start out, again, the steps are D, M, S, B, R. Divide, multiply, subtract, bring down, repeat, or remainder. Again, I'm going to start out with asking the question, how many times will the divisor go into the leftmost digit? I'm going to just remove that comma just for now. It's not going to, right? It's going to give me a result of 0, and so I can just kind of expand my selection. So then I would ask, how many times will it go into 72? Well, it's not going to. So I would expand my selection again. So how many times will it go into 729? Well, that it's going to go into, but I just don't know how many times. So 729 divided by 180 equals what? When we get large numbers like this that we're not used to working with, we have to make educated guesses. What times 180 would give me 729? If I think about 10 times 180, that's going to give me 1,800. That's way too big. But if I cut that in half, it's going to give me 900. So I know that 5 times 180, 5 times 180 is going to give me 900. Now we're trying to get 729, so this is still too big. But I can kind of use it for a basis to say, okay, I can mentally subtract away 180 from this, and I can see that that would work out, right? That would work out because that would put me at exactly 720. So 4 times 180 is 720. And again, check that using vertical multiplication if you don't believe that. So let's do that real quick. So 180 times 4. 4 times 0 is 0. 4 times 8 is 32. 4 times 1 is 4, plus 3 is 7. Okay, 720. So that's as close as I can get to 729 without going over. So I put a 4 directly over that 9. Again, think about your place value. The 9 is in the ones place for 729. That's where the 4 is going to go on top of. Again, think about the fact that when we expanded our selection, we would have had a 0 here and here until we got there to put the 4. Now, we continue the normal way that we would have. And let me go ahead and just put the comma back in the number. We multiply. 4 times 180, again, is 720. We subtract. We know that 729 minus 720 is 9. Then we bring down, and then we repeat. So now we have 180 goes into 90 how many times? Well, again, using whole numbers, we can't do that. So we're going to end up with a 0. So again, 90 divided by 180 would give me 0, remainder of 90. So I put a 0 here. So we multiply. 0 times 180 is 0. We subtract. 90 minus 0 is 90. We bring down. So we bring down this 0 here. And then we're going to repeat, or again, remainder. So in this case, we brought something down. So we're going to repeat. So what is 180 into 900? Into 900. Well, if you remember back from when I did 180 times 10, I said that was 1800 or 1800. Then I kind of mentally just cut that in half in my head and said, okay, well, that's 900. Half of 10 is 5. So 180 times 5 is 900. So I already have my answer there. I already know that it's going to be 5. And again, you can use kind of tricks like this to make educated guesses quickly. Use your trick for multiplying with trailing zeros. I'll always start out with something like 10 or 20 or something like that, and then maybe cut it in half. There's a lot of good mental tricks that you can use to speed this up, especially if you get a test where you're not getting a calculator. Okay, so we know the answer is 5. Let's write that back in. That's going to go right here, and then we're going to multiply. 5 times 180, we know is 900. We subtract, that's 0. And then we'll bring down, but again, when we go up here to try to bring down, there's nothing else up here to bring down. So we know we've finished because it says repeat, which we're not going to do. We didn't bring anything down, or remainder. And we have a 0 here, so there's basically not a remainder. So when we think about 72,900 divided by 180, you get exactly 405. Hello and welcome to Pre-Algebra Test Section 1 on long division. So for our problems, we just want to find each quotient. Okay, for the first one, we're going to do 70 divided by 5. So we're going to start out by setting this up in long division format. So 70 divided by 5. Okay, now what are our steps for long division? So I taught these to you in the lesson. So the first thing you do is you divide, then you multiply, then you subtract, then you bring down, and then you're going to repeat, meaning go back up to division and go down, or you're going to have a remainder. You're going to have a remainder. And sometimes you won't have a remainder. Sometimes it'll be 0, and basically this just tells you, hey, we're done with the problem. So let's start out. We're going to start out at step number 1 where we divide. So we're always taking long division. Basically, you're thinking about the dividend by breaking it up into a digit at a time. So you're going to ask, how many times will 5 go into the leftmost digit of that dividend? In this case, it's the 7. So basically, 5 goes into 7 is the same thing as saying, what is 7 divided by 5? Well, 7 divided by 5 would be 1. Okay, would be 1 with a remainder of 2. Okay, 1 with a remainder of 2. But when we're working with long division, we don't think about the remainders until the very end. So you just put the quotient part. So we would say 5 goes into 7 just once, and then we multiply. So we're going to multiply the 1 times the divisor. So our answer times the divisor, 1 times 5 is 5, and we put it directly beneath that 7 that we were just working on. Now we're going to subtract. 7 minus 5 is 2, and then we bring down. And when we say bring down, we bring down the next digit to the right. So now we have the number 20, and this is what we're going to work with when we say repeat or remainder. We're not going to have a remainder yet because we're not done, so we're going to repeat. So we basically just go back up and we divide. So now we're looking at 5 goes into 20, okay? And that's basically the remainder from our first division, and then we tacked on the 0 to get that number 20. So 5 goes into 20 how many times? Well, it's going to go in exactly 4 times. Now we multiply. 4 times 5 is 20. Then we subtract. 20 minus 20 is 0. We go to bring down, but there's nothing else over here. So now instead of the repeat, we go to remainder. And the remainder is basically 0, meaning we just don't have one. So we're done with our problem. 70 divided by 5 is 14. And again, to check your division, use multiplication. Remember, you can go backwards. So if 70 divided by 5 equals 14, that means 14 times 5 should equal 70. 5 times 4 is 20. 5 times 1 is 5, plus 2 is 7, and we do get 70. All right, next let's look at 312 divided by 4. So 312, and we're dividing this by 4. And again, our steps would be to divide, and I'm just going to put the first letter of the word. So D, multiply, M, subtract S, bring down B, and then repeat or remainder R. And again, a lot of people just remember this using the family. Dad, mom, sister, brother, and then Rover is the dog. Okay, so we will start our division by dividing. So we'll say, how many times does the divisor go into the leftmost digit, 3? So essentially, I taught you in the lesson, if the answer is going to be 0, you can just expand your selection. Because if you say, what is 3 divided by 4, you get 0 remainder of 3. Okay? In other words, thinking about this with the boxes, if I had 3 boxes, and I said, how many equal groups of 4 can I make? Well, if I'm not using fractions or decimals, I can't make any, right? I can't make any. I don't have enough to make a group of 4. So the answer would be 0. And so what we do is we expand this to include the 3 and the 1. So now we're going to ask the question, how many times does 4 go into 31? So 31 divided by 4 equals what? Again, turn that around. What times 4 equals 31? 8 is going to be too big, so we're going to go with 7. Okay, we're going to go with 7. Now, where do I put my answer? Do I put the 7 here? No, I do not. Remember, we should have had a 0 here, but we kind of used a shortcut, so we got to make sure that we put the 7 on top of that 1. Just think about this number 31. Where's the 1's place? The 1's place is here, where that 1 is. So we're just lining the 7 up with the 1's place from 31. Okay, now we're going to go through and multiply. And we take the answer here that we got, and we're going to multiply it by the divisor. 7 times 4 is 28. line that up with the 31 we were just working with, and then we subtract. 31 minus 28 is 3. Now we're going to bring down, so we bring down that 2 there. And basically we repeat, so we go back up to the top. So now we're going to divide. 4 goes into 32 exactly 8 times. 8 times 4 is 32. Subtract, you get 0. And at this point, there are no more numbers to bring down. So this would be our remainder if we had one. It's 0, so there is no remainder, and we stop. So 312 divided by 4 is exactly 78. And again, if you want to check that, just use multiplication. So 78 times 4 should give us 312. 4 times 8 is 32. 4 times 7 is 28, plus 3 is 31. And of course, we do get 312 as our result. Okay, for the last problem, we look at 121 divided by 11. So 121 divided by 11. And again, our steps are going to be to divide, multiply, subtract, bring down, and then repeat or remainder. Dad, mom, sister, brother, Rover. So 11 goes into 1 how many times? Well, it's going to be 0. So we're going to move on, and we're going to expand our selection to include the 1 and the 2. So we're going to ask, how many times will 11 go into 12? It goes in just once. So where we're going to put the 1 at? Are we going to put it right here? No, of course not. Because remember, we would have had a 0 here if we would have went through and said, okay, 11 goes into 1 0 times, went through the multiplication, all that stuff. We'd ended up asking, how many times does 11 go into 12 anyway? So we make a shortcut and we just say, okay, how many times does 11 go into 12? It goes in once. So we put that 1 into the ones column for 12. Okay, it's got to line up there. Now we multiply. 1 times 11 is 11. And line that guy up underneath the 12 that you're working with and subtract. 12 minus 11 is 1. Then we bring down. Okay, bring down that 1. And then we're going to repeat. So we go back up to division. 11 goes into 11 how many times? Well, any number divided by itself, except for 0, is going to be 1. So I'm going to put a 1 there. Then I'm going to multiply. 1 times 11 is 11. Subtract, you're going to get 0. Nothing else to bring down. And so our remainder is 0. So we know that 121 divided by 11 is 11. So again, we can check this. 11 times 11. 1 times 1 is 1. 1 times 1 is 1. Move over. 1 times 1 is 1. 1 times 1 is 1. Just do some addition. This comes down. This will be 2. And this is 1. So we do, in fact, get 121 as our answer. Hello, and welcome to Pre-Algebra Test Section 2 on long division. Okay, for the first problem, we have 197 divided by 12. So set this up in long division format, 197 divided by 12. And remember your steps. You're going to divide. You're going to multiply. You're going to subtract. You're going to bring down. Then you're going to repeat, meaning go back up to divide and start over, or you're going to have a remainder. And including that would be, if you didn't have a remainder, let's say the remainder is 0. Basically, this part just tells you, hey, I didn't have anything else to bring down, so I'm done with the problem. Okay, so remember, there's a trick to remembering that, and you basically just use your family members. Divide, we would say dad. Multiply, we would say mom. Subtract, we'd say sister. Bring down, we'd say brother. And then repeat or remainder, you use the family dog Rover. All right, so let's start out with divide, our first step. And we look at 12, our divisor, and we ask how many times will it go into this leftmost digit of the dividend. Okay, we're taking this basically 1 digit at a time. So 12 goes into 1 0 times. So essentially I can put a 0 here, or as I told you in the lesson, I can just expand my selection to 19. Now I would ask, how many times does 12 go into 19? Well, it's going to go in only once. Okay, only once. Because if I think about 12 times 1, I would get 12. 12 times 2 would be too large. It would be 24. That's bigger than 19. So it has to be 1. Now I want you to notice where I wrote that 1 at. I wrote it directly above the 9 because remember, this is the ones place for the number we're working with, which is 19. So you got to line that 1 up. Another thing you can think about is I would have had a 0 here if I wouldn't have used my shortcut. when I said 12 goes into 1 0 times, I would have put a 0 there. Remember, a 0 to the left of this 1 doesn't change the value of the number. So I can just erase it. I don't need it. Now, let's go through our steps. We've done the division. Now we want to multiply. So we take our answer, multiply by the divisor. 1 times 12 is 12. And we're going to write it underneath the 19 that we were working with. So now we're going to subtract. 19 minus 12 is 7. Then we bring down. So bring this 7 down. And now we're going to repeat. Right? We're going to repeat. So bring this back up here and think about, okay, now I have 12 goes into 77. How many times? So 77 divided by 12 equals what? What times 12 equals 77? So some of you know the times tables for 12. Some of you don't. A lot of you will know that 5 times 12 is 60. So 6 times 12, if you just added 12 more to 60, would be 72. That's going to be as close as we can get. So we're going to put a 6 here. And then we're going to just follow our steps. We're going to multiply. 6 times 12, as we just said, is 72. We're going to subtract. 77 minus 72 is going to be 5. And then we're going to bring down. But there's nothing else over here to bring down. So we come to our last step where normally we would repeat. But in this case, we can't repeat because we didn't bring anything down. So we go to this remainder. So 5 is what's left over. And again, just think about what's happening when you perform a division. You're taking 197 and you're saying, hey, split this up into equal groups of 12. Well, I made 16 of those. So let's think about 16 times 12. 2 times 6 is 12. 2 times 1 is 2, plus 1 is 3. Then moving to the left, 1 times, basically think about this 1 times 16, because 1 times anything is just itself. I can just write a 6 and then a 1 here. Bring the 2 down. 3 plus 6 is 9. Bring down the 1. So I only used 192 out of the 197 items that I had, okay, when I split it up in equal groups of 12. What happens is this 5, the difference between 197 and 192, is just what's left over. I have 5 more items just hanging out. And to make another group of 12, I would need another 7. I don't have it, so this is just a remainder. Okay? So again, if you were to check something like this, you'd go through a multiply, then add your remainder back in, and you get back to the dividend. Okay, for the next one, we have 1,505 divided by 301. So 1,505 divided by 301. Again, your steps: divide, multiply, subtract, bring down, and repeat or remainder. Dad, mom, sister, brother, Rover. So take the 301 and ask how many times will it go into the leftmost digit. It's not, so we can put a 0 here if we want and go through all the steps, but essentially the shortcut is just to expand the selection. So we can say, okay, well, how many times will it go into 15? It's not going to. How many times will it go into 150? It's not going to. So we have to go all the way out and use the entire dividend and say, how many times will 301 go into 1,505 or 1,505? Well, to answer that question, since these are relatively large numbers, we kind of have to take an educated guess. So 1,505 divided by 301 equals what? Now I can eyeball this and see the answer, but you might not be that good at mental multiplication. So if you think about what times 301 equals 1,505, just kind of estimate, okay? Just think about 301 as 300. Now we've got some trailing zeros going, and I can say, okay, well, so what times 300 would get me close to 1,500? Well, 5 would. 5 times 3 is 15, and then just attach 2 zeros to the end. Now, one thing you can see if you eyeball, 5 times 1 is 5, so it looks like that's going to work out perfectly. Right? If we do 301 times 5, 5 times 1 is 5, 5 times 0 is 0, 5 times 3 is 15, so we do in fact get 1,505. So we come back up here, and we think about what goes here. Well, we're going to put a 5, and notice where I put it. I put it, since we use the entire number here, I'm thinking about the ones place for the entire number, which is the 5, and I'm lining it up there. And alternatively, you could have think about, okay, well, I would have had a 0, a 0, and a 0 here if I didn't use the shortcut. So make sure you line that up correctly. Now we're going to multiply. 5 times 301 is 1,505. We're going to subtract. We get 0, nothing to bring down. So we have no remainder. Essentially, 1,505 divided by 301 is 5. And again, we could check that with multiplication, but we basically just did the problem. So we know we have the correct answer here. Hello and welcome to Pre-Algebra Test Section 3 on long division. So we want to find each quotient, and we just have one problem to do. We're looking at 1,444,014 divided by 7,722. Let's look at our steps for long division. Again, we want to start out by doing some division. So I put divide. Then we want to multiply. Then we want to subtract. Then we want to bring down. Okay, bring down. Then we want to repeat the process, meaning go back up to divide, or remainder. All right, so let's set up the long division here. 1,444,014, and then 7,722. I'm going to remove these commas just for a second. We would start by asking, how many times will this divisor go into this leftmost digit? It's not going to go. So we could put a 0 here and go through all the steps. But essentially what's going to happen is the shortcut is just expand the selection until you find something that it's going to go into. Not going to go into 14, not going to go into 144, not going to go into 1,444. It will finally go into this number right here, 14,440 divided by 7,722. We can do that. Okay, so how do we guesstimate something like this? Well, I could take 7,722 and just kind of eyeball and look at it and say, okay, well, at most, this is going to go in to 14,440 twice, at most. So we'll multiply this by 2 and see what we get. If it's more than this, we're just going to use 1. 2 times 2 is 4. 2 times 2 is 4. 2 times 7 is 14. 2 times 7 is 14 plus 1 is 15. So we get a number or a value that is larger than this. So we're going to have to use 1 because that will not go over. Okay, so we're going to use 1. Now again, where are we going to write the 1 at? We're going to write it directly over the 0, which is in the ones place for this number that we have, 14,440, right? The one that we are using for our division. Now, let's erase this real quick and we'll put our commas back into the number. And let's go through the steps. We want to multiply. 1 times 7,722 is 7,722. Now you have to line this up properly. So the 2 is in the ones place. This 2 is in the tens place. This 7 is in the hundreds place. And this 7 is in the thousands place. And again, we're just thinking about this number right here. Everything is relative to that, which we created right now. Okay, so we're going to subtract. 0 minus 2, we need to borrow. So this becomes 3. 10 minus 2 is 8. 3 minus 2 is 1. We'll borrow here. This will become 14. Then we'll take 1 away and it'll become 13. So then this will become 14. 14 minus 7 is 7. And then 13 minus 7 would be 6. So we get 6,718. Okay, so now we're going to bring down. And we're going to repeat. So now we're going to divide. We have 7,722 going into 67,181. So these are big numbers. So again, you have to use some guesstimation. So let's scroll down a little bit and just think about 7,722 times what would give me this number. Well, if I drop the 22 off and just kind of think about this number as 7,700, I have some trailing zeros here, so it becomes easier to multiply by some numbers to get close. So let's think about if I multiply this by 6, what would that give me? 6 times 0 again is 0. 6 times 0 is 0. 6 times 7 is 42. 6 times 7 is 42 plus 4 is 46. So we get 46,200. That's pretty low. So we're going to adjust our guess. And I'm going to adjust it to 9. So 9 times 0 is 0. 9 times 0 is 0. 9 times 7 is 63. 9 times 7 is 63 plus 6 is 69. So we get 69,300. That's too big. So I'm going to adjust my guess again down to 8. And that's in fact going to work. Right? So 8 times 0 is 0. 8 times 0 is 0. 8 times 7 is 56. 8 times 7 is 56 plus 5 is 61. So we get 61,600. That's as close as we can get to this without going over. So we're going to use 8 as our answer. Put an 8 right there. And let me kind of erase all this stuff. So we do our multiplication. 8 times 7,722, as I just showed you, was 61,776. Now we're going to subtract. So borrow from the 8. 11 minus 6 is 5. 7 minus 7 is 0. Borrow from the 7. 11 minus 7 is 4. 6 minus 1 is 5. So we end up with 5,405. 5,405. And now we're going to bring down. Bring this 4 down to give us 54,054. And then one more time, we're going to repeat this and do a division. So 54,054 divided by 7,722. What would that give us? Well, looking at this, which is the result of multiplying 7,722 by 8, it looks like I can get away with multiplying it by 7. Seems like that would be close without going over. So let's check that out. So we would have 7,722 times 7. 7 times 2 is 14. 7 times 2 again is 14, plus 1 is 15. 7 times 7 is 49, plus 1 is 50. 7 times 7 is 49, plus 5 is 54. So we actually end up with the exact amount, 54,054. And so 7 will go up here. We'll multiply. 7 times 7,722, as I just told you, is 54,054. We'll subtract. We get 0. Nothing else to bring down, and basically we're done. Our remainder here is just 0. We don't have our remainder. So 1,444,014 divided by 7,722 is exactly 187. And if you want to check this, just go through and do a vertical multiplication. Do 187 times 7,722, and you will get this back, the 1,444,014. Hello and welcome to Pre-Algebra Test Section 4 on long division. Okay, we just want to find each quotient, and we're only going to have one problem here. We're going to take a look at 996,325 divided by 703. So let's set this up in long division format. 996,325 divided by 703. So the steps for doing a long division, as I've told you, you have divide, multiply, subtract, bring down, and then repeat or remainder. And a lot of people say dad, mom, sister, brother, and then rover, kind of thinking about the family, to remember the steps. All right, so we're going to start out by asking how many times will the divisor, which is 703, go into the leftmost digit of this number? Well, it doesn't, right? So you can put a 0 here and go through the steps, or you can kind of just expand your selection. Either way, you're going to get the same answer. You're going to end up with zeros to the left of your first non-zero number, and it wouldn't change the value. Meaning if I had something like 001, that's still 1, right? I can just drop the zeros off. So kind of the shortcut would be just expand the selection and just say, okay, well, how many times would 703 go into 99? Well, it wouldn't. So I would expand my selection again and say, well, how many times would 703 go into 996? Well, just once. Okay, just once. All right, so and think about why I put that 1 directly over the 6. Well, I would have had a 0 here and a 0 here, so my 1 would have laid there. But another way to think about it is, you're working with the number 996. Where's the 1's place for that number? It's going to be the 6 there. So you're going to line up the 1 with the 1's place, so it will go over that 6. Okay, so now let's go through and do the steps. We're going to multiply. So we take 1 and multiply it by 703. That gives us 703. And then we subtract. So 996 minus 703. 6 minus 3 is 3. 9 minus 0 is 9. 9 minus 7 is 2. So now we're going to bring down. So you always bring down your next digit to the right. So you bring down this 3. And basically the R tells you repeat or remainder. In this case, we have something new to work with. So we're going to repeat. We basically go back up to the top and we start dividing again. So we say, how many times will 703 go into 2,933? So 2,933 divided by 703 is equal to what? Well, working backwards, think about what would get me close. What times 703 would get me close to 2,933 without going over, But when we work with larger numbers than say single digit or 2-digit numbers, we kind of have to guesstimate a little bit. So if I think about what 5 times 700 would be, that's 3,500, that's too big. So what about 4 times 700? That's 2,800. So if I think about 703 times 4, I think that would work. 4 times 3 is 12. 4 times 0 is 0, plus 1 is 1. 4 times 7 is 28. So 2,812. So we're going to use a 4 as the answer because 5 would be too big. Okay, let's go up here. So we're going to put a 4 here. Then we're going to follow the steps again. We're going to multiply. 4 times 703, because I just showed you was 2,812. Then we subtract. 3 minus 2 is 1. 3 minus 1 is 2. 9 minus 8 is 1. So now we're going to bring down. We have this 2 to bring down. And we have 1,212. And we're going to repeat the process now. So we go back up to division. And we say, how many times will 703 go into 1,212? Now, just from estimation, I know that if I double 700, I get 1,400 or 1,400. That's too big, okay? So this will only go into this one time, just once. 1 times 703, following the steps, would give me 703. Then subtract. This will become 12. 12 minus 3 is 9. 0 minus 0 is 0. Borrow here. 12 minus 7 is 5. So we get 509. Now we want to bring down. And for one last time, we're going to repeat. And we're going to ask, how many times will 703 go into 5,095? So how many times will 703 go into 5,095? I'm going to just think about 703 as 700, so I can kind of guesstimate a little bit. So 5 times 700 is 3,500. And again, you can do that in your head by thinking about the trailing zeros. 5 times 7 is 35. Put 2 trailing zeros in the end, it's 3,500. So that's too small. Let's say I go with 7. 7 times 7 is 49. Put 2 zeros at the end, it's 4,900. That's about as close as I'm going to get to this. So let's think about 7 times 703. 7 times 703. 7 times 3 is 21. 7 times 0 is 0, plus 2 is 2. 7 times 7 is 49. So 4,921. 4,921. Let's come back up here and write a 7, and then multiply. 7 times 703, as I just showed you, was 4,921. And then we're going to subtract. 5 minus 1 is 4. 9 minus 2 is 7. We'd borrow here. 10 minus 9 is 1. And we go back up here to bring down. Nothing else over here. So remember, the last step says repeat or remainder. So if we had something else to bring down, we would repeat. But there's nothing else to bring down, so we just consider this last amount here the remainder. So we have 174 left over. So again, think about what this is saying. I had 996,325 of something. Let's say there were boxes. I keep saying that. We split it up into equal groups of 703. What I was able to form is 1,417 of these groups. And then essentially I had 174 of them. I had 174 boxes just left over. I can't make another group of them because I need a 703 to make a total group. So that is just my remainder. Now, if we wanted to check this, what we do is we take 1,417, we'd multiply it by 703. And then once we have that result, we'd add the remainder to it. So plus 174, and that would get us back to this dividend here. Hello and welcome to Pre-Algebra Test Section 5 on long division. All right, so we want to just find each quotient. And we have 13,576,282 divided by 111. All right, so let's set this up in long division format. So 13,576,282. Again, we're dividing this by 111. Now remember your steps when you're doing a long division. You have divide, multiply, subtract, bring down, and then repeat or remainder. Again, kind of the trick that everyone uses is dad, mom, sister, brother, rover. Right? So you think about the family. Okay, so we begin by looking at the divisor and asking how many times will it go into the leftmost digit of the dividend. So as I've told you in probably every video, you could put a 0 here if you wanted to, because 111 is not going to go into 1, okay, when we think about using whole numbers. So you could put a 0 there and you could multiply and subtract it, but what's going to happen is you're going to end up with all that, a 13 here, just the same thing as if you expanded that. So you can kind of use a shortcut and just say, okay, well, it's not going to go into 1, so we just expand and say, will it go into 13? Not going to go into 13. Will it go into 135? Well, the answer is yes. It will go into 135 just once, though. So I put a 1 here directly above the 5. Again, thinking about the number 135, the 5 is in the 1's place. That's where we want to put our 1. Alternatively, you could say, well, I skipped this over. This should have been a 0. I skipped this over. This should have been a 0. So my 1 would have been right there. Either way, again, you put the 1 directly on top of that 5. Okay, now we multiply. 1 times 111 is 111. Then we subtract. 5 minus 1 is 4. 3 minus 1 is 2. And then we bring down. So bring down this 7 here. And then we repeat. So we go back up and we divide. So now we're going to ask how many times will 111 go into 247? That's going to be twice, right? You think about 111 times 2. It's all ones up here, so it's pretty easy to do. You're going to end up with 222. Right? You can kind of do that in your head. 2 times 1 is 2, 2 times 1 is 2, 2 times 1 is 2. 222. Okay, so we go through and we multiply. 2 times 111 is, again, 222. We subtract. 7 minus 2 is 5. 4 minus 2 is 2. And then we bring down. So now we're going to bring down a 6. So we have 111 goes into 256. Again, that's going to be twice. Because I can eyeball this and say, okay, I know 3 times 111 is 333. Again, you're multiplying by a 1, a 1, and a 1. So if I multiplied by 3, I get 333. Now, again, using this, I know that the answer is going to be 2. 2 times 111 would give me 222. We subtract. 6 minus 2 is 4. 5 minus 2 is 3. And then we bring down. So bring down this 2. And I'm going to be scrolling back and forth, so I apologize if anything gets cut off. Hopefully you have this written down on your paper and you can keep up. So 111 now is going to go into, and let me scroll down, 342 how many times? So 342 divided by 111 equals what? Well, as I just showed you, 111 times 3 would be 333, right? 3 3s in a row. That's as close as we can get to 342 without going over, because 111 times 4 is going to be 444. So we're going to put 3 as our answer. Come back up here, put a 3, and we multiply. 3 times 111, as I just said, was 333. Subtract. We're going to borrow here. 12 minus 3 is 9. And then these would both be 0. 3 minus 3 is 0. 3 minus 3 is 0. So we have a 9 there. So now we're going to bring down again. So we have this 8 that's coming all the way down here. All the way down here. And then we want to repeat. So 111 goes into 98 how many times? Well, it's going to be 0. If I have 98 of something and I try to split it up into equal groups of 111, using whole numbers, I can't do that, right? So the answer would be 0. So I put a 0 here, and then I go through the steps. I multiply. 0 times 111 is 0. So this is 0. And I know it's cut off, but the next step is to subtract and then bring down. So this will be 98. And then we bring down. So I have this 2 here to bring down, all the way down here. All the way down here. So we have a 2 there. And basically the next step is to repeat, right? The R. So how many times will 111 go into 982? Well, that's pretty easy. I know that 111 times 9 is 999. 9 times 1 is 9, 9 times 1 is 9, 9 times 1 is 9. Again, you can do that in your head. So that's too big. That's bigger than 982. So it has to be 8, right? It has to be 8. So we'll put an 8 as our answer right here. And then we multiply. 8 times 111 is 888. 888. Again, easy to do that in your head because you're just multiplying by 1. 8 times 1 is 8. 8 times 1 is 8. 8 times 1 is 8. So subtract here. We'll borrow from the 8 and get a 7. This becomes 12. 12 minus 8 is 4. Borrow from the 9 and get an 8. 17 minus 8 is 9. So we end up with 94. And when we look back up here, there's nothing else to bring down. So we get to our final step, which says repeat or remainder. There's nothing to repeat because I didn't bring anything down. So remainder is just 94. Okay, the remainder is 94. Let me erase this real quick, and I'll write the remainder up here. So essentially what happens is I took 13,576,282. I split it into equal groups of 111. I got 122,308 of them, and then I had 94 left over. Now again, to check this, you would multiply the 122,308 by 111. Then when you get that result, you would add your remainder back to that, and that will give you the original dividend, which is 13,576,282. And go ahead and try that for yourself at home. Hello and welcome to Pre-Algebra Practice Set number 15. In this video, we're going to look at some additional practice problems for the lesson that we did on the Introduction to Exponents. Okay, so we're going to start out with some pretty easy problems. We want to just identify the base and exponent in each. So remember, when we're talking about a number like 9 to the 7th power, the number 9, this bigger number, is referred to as the base. The number 7, this smaller number, is referred to as the exponent. Remember what this is telling me. It's telling me that 9 is multiplied by itself 7 times. So 9 to the 7th power is 9 times 9 times 9 times 9 times 9 times 9 times 9. Again, 7 factors of 9. So this number right here, the 9, is the base. That's the number we're multiplying by itself. And then again, 7, the exponent, tells me how many factors of the base that we have. So what about 6 to the 3rd power, or as I told you in the lesson, we say this is 6 cubed. The 6 is the base. This is the base. Again, that's always the bigger number. And then the smaller number is the exponent. Again, this tells me I have 3 factors of 6. Okay, what about 8 to the 4th power? So again, the bigger number, 8, is your base. That is the number that's being multiplied by itself. And then 4, the smaller number, is the exponent. This is the exponent. So this would be 8 times 8 times 8 times 8. Right, that would be 8 to the 4th power. Again, the base is 8 because that's what's being multiplied by itself. And 4 is the exponent. That tells you how many factors of 8 that you have. Okay, now we want to write each in exponent form. So we have 9 times 9 times 9. So the number that's being multiplied by itself is 9. Again, that's the base. So I'm going to write that as the bigger number. Then the number of factors we have 1, 2, 3. That's our exponent. That's the little small number up in the top right corner. So this would be 9 to the 3rd power, or 9 cubed. What about this one? 3 times 3 times 3 times 3 times 3 times 3 times 3. So my base here, the number that's being multiplied by itself, is 3. Right? That's your bigger number. Then how many factors of 3 do I have? I have 1, 2, 3, 4, 5, 6, 7. So this is going to be 3 to the 7th power. Again, the exponent, the smaller number, is telling you how many factors of 3 that you have. Okay, for the next one, we have 7 times 7 times 7 times 7. And again, it's really simple. The base is the number that's being multiplied by itself. So that's 7. That's your bigger number. Then the small number is the number of factors you have. So you have 1, 2, 3, 4. 4 is the exponent. So we have 7 to the 4th power. Okay, now we're looking at 4 times 4. So the number that's being multiplied by itself is 4. And we have just 2 factors. So the exponent is 2. So this is 4 to the 2nd power, or as we refer to it as, 4 squared. Okay, now let's look at 6 times 6 times 6 times 6 times 6. So again, the bigger number is going to be 6, right? That is the number that's being multiplied by itself, called the base. And then we have 1, 2, 3, 4, 5 of these. So that's going to be your exponent. Right? Your exponent is going to be 5. That's telling me how many factors of 6 that I have. Okay, now we want to write each as a repeated multiplication. And so we're going to start out with 1 to the 9th power. So what would this be? The base tells me what I'm multiplying by itself. So I know I'm going to be multiplying 1 by itself. And then the exponent tells me how many times. So 9 tells me how many times. So I'm going to have 9 factors of 1. So that's 3, 4, 5, 6, 7, 8, and then 9. Let me make sure I did that right. I got 1, 2, 3, 4, 5, 6, 7, 8, and 9. So 9 factors of 1, that's 1 to the 9th. What about 7 to the 2nd power, or 7 squared? Well, that's going to be 2 factors of 7, right? So 7 times 7. What about 2 to the 4th power? 2 to the 4th power. Again, 2 is the number that I'm multiplying by itself. 4 is the number of times I'm doing that. So we'd have 2 times 2 times 2 times 2. What about 15 to the 3rd power, otherwise known as 15 cubed? Well, again, I'm just going to take this number, the base, and multiply it by itself this number of times. So 15 times 15 times 15, and we're done. What about 18 to the 5th power? Again, I'm just going to take the base, which is 18, multiply it by itself 5 times. So 18 times 18 times 18 times 18 times 18. So now we want to evaluate each. That just means find out the value. So how do we find the value for 2 to the 5th power? Well, basically all we need to do is write this using multiplication. 2 to the 5th power is 5 factors of 2. So 2 times 2 times 2 times 2 times 2. And then we just multiply. And a lot of these, especially with 2 as the base, you'll memorize those very quickly because you use them all the time. 2 to the 5th power is 32. And I know that from memory, but you can go through and multiply. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. What about 3 to the 3rd power, or 3 cubed? So again, this is 3 factors of 3. 3 times 3 times 3. And just multiply. 3 times 3 is 9. 9 times 3 is 27. What about 4 squared? 4 squared is 4 times 4, which is 16. What about 5 to the 4th power? So this is 5 times 5 times 5 times 5, right? 4 factors of 5. 5 times 5 is 25. 25 times 5 is 125. And then for memory, I know that 125 times 5 is 625. But if you don't know these things, you can always go through and just do the vertical multiplication. It takes a little bit of time, but over time, things like this, like 5 cubed, 5 to the 4th, 2 to the 5th, 2 to the 6th, these things that come up over and over and over again, you're going to memorize them very, very quickly. What about 10 to the 9th power? Well, I told you a little trick for this in the lesson. If I have 10 as a base, and I have a whole number exponent that is larger than 1, so meaning 2, 3, 4, 5, 6, so on and so forth, basically all I need to do is write down a 1 and follow it with this many number of zeros. So my exponent is a 9, so I would follow that one with 9 zeros. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Comma, comma, comma. So you end up with 1 billion as your answer. Okay, final problem. Again, we're using the same trick. We have 10 to the 13th power. So all I need to do here is write a 1 and follow it with this many number of zeros. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and then 13. Put in my commas. And we end up with 10 trillion. Hello and welcome to Pre-Algebra Test Section 1 on the Introduction to Exponents. Okay, so we want to just identify the base and exponent in each. Okay, so we're going to start out with 1 to the 4th power. So for 1 to the 4th power, this bigger number here is known as the base. This smaller number here, the 4, is known as the exponent. The exponent. And remember the definition. If I have something like 1 to the 4th power, it's telling me I have 4 factors of 1, or 1 multiplied by itself 4 times. The base, again, the bigger number, is the number that's being multiplied by itself. And the 4, the exponent, is how many times I'm doing that, right? How many factors of 1 do I have? I have 1, 2, 3, and then 4. Next, we're going to look at 2 to the 15th power. Again, the bigger number is known as the base. This is the number we're multiplying by itself. And then 15, that smaller number, is the exponent. So for this one, it's telling me that I have 2 being multiplied by itself 15 times. So if we were to write that out, you'd have 2 times 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 2. How many is that? 1, 2, 3, 4, 5, 6, 7, 8. So that would be 15 factors of 2, or 2 to the 15th power. And you can see where exponents help us. It's a lot more convenient to write this than to have to go through and write all of that. Okay, what about 8 to the 7th power? Again, 8, this big number, is known as the base. That's the number we're multiplying by itself. And then 7, the smaller number, is the exponent. This is how many factors of 8 we're going to have. What about 9 to the 19th power? Again, 9, the bigger number, is the base. And then 19, that smaller number, is your exponent. So I would have 19 factors of 9. Okay, last one. We have 10 to the 12th power. And the bigger number here, the 10, is the base. And the smaller number, the 12, is the exponent. So this is telling me I have 12 factors of 10. Hello and welcome to Pre-Algebra Test Section 2 on the Introduction to Exponents. Okay, so for the problems today, we want to write each in exponent form. So we begin with 2 times 2 times 2. And so to write this using exponents, the big number, or the first number we're going to write, is 2. That is called the base, and this represents the number that's being multiplied by itself. In this case, it's 2 times 2 times 2. 2 is being multiplied by itself, so that's our base. The second number we're going to write is the exponent. That's going to go in the top right corner. It's going to be a small number, and it's going to tell us how many factors of the base we have. We have 1, 2, 3 of them. So I'm going to put a little small 3 right there. This is my exponent. Okay, so we read this as 2 to the 3rd power, or 2 cubed, and that's 2 times 2 times 2. Okay, let's look at 15 times 15 times 15 times 15 times 15. So the base here will be 15. That's the number that's being multiplied by itself. And then we have 1, 2, 3, 4, 5 factors of 15. So 5 will be the exponent. Again, this is the base. That's the number we're multiplying by itself. That's 15. And then we have 5 of these, right? We have 5 factors of 15. So 5 is our exponent. What about 7 times 7? Well, the number that's being multiplied by itself is 7. And we have 2 factors, right? We have 7 times 7, so the exponent is 2. Again, 7 would be the base, and 2 would be your exponent. What about 8 times 8 times 8 times 8 times 8 times 8? Well, again, the number that's being multiplied by itself is 8, so that is going to be our base. That is our base. And then we do this 1, 2, 3, 4, 5, 6. We have 6 factors of 8, so 6 is the exponent. 6 is the exponent. Okay, so I had to shrink down the font a little bit just to show this to you. We have 10 times 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 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 factors of 10. So to write this using an exponent, the base is 10, right? The base is 10. That's the number we're multiplying by itself. And then the exponent is 10, right? Because we have 10 factors of 10. So the exponent is also 10. Hello and welcome to Pre-Algebra Test Section 3 on the Introduction to Exponents. All right, so for the problems today, we want to write each as a repeated multiplication. And we start out with 215 to the 3rd power, otherwise known as 215 cubed, right? When we have something to the 3rd power, we generally say it's cubed. So what do we want to do here? Well, we're just going to write this using multiplication. So the 215, the base, is the number that we're multiplying by itself. And the 3, the exponent is the amount of times that 215 is going to be a factor. So we have 215 times 215 times 215, right? 3 factors of 215. And that's what 215 to the 3rd power, or 215 cubed, is telling me I have. What about 100 squared? Well, that's just 2 factors of 100, right? It's this number here, the 100, the base, times itself. 100 times 100. 2 factors, again, that's what the exponent's telling me, 2 factors of 100. What about 9,000 to the 5th power? Well, that's just 5 factors of 9,000. So 9,000 times 9,000 times 9,000 times 9,000 times 9,000. And that's 5 of them, right? I got 9,000 times 9,000 times 9,000 times 9,000 times 9,000. So 5 factors of 9,000. What about 14 to the 7th power? So that's just going to be 7 factors of 14. So 14 times 14 times 14 times 14 times 14 times 14, and then times 14. Again, 7 factors of 14. Okay, last one. We have 19 to the 4th power. So this is, again, is just telling us we have 4 factors of 19. So we write this as 19 times 19 times 19, and then times 19. 1, 2, 3, 4 factors of 19. Hello and welcome to Pre-Algebra Test Section 4 on the Introduction to Exponents. Okay, so for the problems today, we just want to evaluate each, which means we're just going to find the value. So we're going to start out with 10 to the 4th power. So normally what we do is we just go through and we write this using multiplication, and then we solve the multiplication. But when we have 10 as a base, and we have a whole number exponent that's larger than 1, we can use a little trick. And I taught you this in a lesson. Basically, what you want to do is write the number 1 and follow it with the exponent number of zeros. So if I have a 4 as an exponent, I would put 1, 2, 3, 4 zeros, and I'm done. I end up with the number 10,000 as a result. And if you want to go through and prove that to yourself, you can do it the long way. 10 to the 4th power tells me I have 4 factors of 10. So 10 times 10 times 10 times 10. And using our trick from the lesson where we learned about multiplying with trailing zeros, we would have 1, 2, 3, 4 factors of 1. So that would just be 1, right? 1 times 1 times 1 times 1 is just 1. And then you would attach 1, 2, 3, 4 trailing zeros. 1, 2, 3, 4. And again, you end up with 10,000. Okay, what about 3 to the 3rd power, otherwise known as 3 cubed? Well, basically all I'm going to do is multiply 3 by itself 3 times. So 3 times 3 times 3, right? 3 factors of 3. 3 times 3 is 9. 9 times 3 is 27. What about 9 to the 2nd power, or otherwise known as 9 squared? This is just 2 factors of 9. So 9 times 9, and that's 81. Okay, let's look at 13 squared. So this is going to be 13 times 13, right? 2 factors of 13. And you can do this using vertical multiplication. I happen to know the answer is 169 off the top of my head, just through memorization. But if you were to do this with a vertical multiplication, again, pretty simple. 3 times 3 is 9. 3 times 1 is 3. Then I'm multiplying 1 times 13. I'm just moving it over. So 1 times 3 is 3. 1 times 1 is 1. And you just bring down the 9. 3 plus 3 is 6. Bring down the 1. And of course, you get 169. Okay, last one is 2 to the 5th power. And this one's pretty easy. I've memorized this. I know it's 32. And you'll memorize this one pretty quickly too. But again, it's 5 factors of 2. So 2 times 2 times 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. And then 16 times 2 is 32. Hello and welcome to Pre-Algebra Test Section 5 on the Introduction to Exponents. Okay, for the problems today, we just want to evaluate each. And again, that just means to find the value for. Okay, so we start with 10 to the 15th power. And again, I've shown you a trick for this in the lesson and in a couple other videos that we did in this series. Essentially, if you have 10 as your base, and you're raising it to an exponent that's a whole number that is larger than 1, so 2, 3, 4, 5, 6, so on and so forth, you can use a little trick. Basically, you just write a 1 followed by this number of zeros. Okay, so whatever the exponent is, you follow it with that number of zeros. So you'd have 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And I can't fit that way. Let me kind of start this over. A 1 followed by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 zeros. So comma, 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 comma. That is a really big number. And this trick saves you a lot of time. You don't have to go through and write out 15 factors of 10, then try to multiply them. Obviously, you can multiply them using the trick for multiplying with trailing zeros, but still writing all that stuff out is time consuming. So in case you don't know what this number is, you can kind of look here. This is the hundreds place. This is the hundred thousands place. This is the hundred millions place. This is the hundred billions place. This is the hundred trillions place. So what comes to the left of that? It's called the quadrillions place. So this would be 1 quadrillion. Okay, now we have 3 to the 4th power. So again, the exponent tells me how many factors of 3 I have. So 3 to the 4th power tells me I have 4 factors of 3. 3 times 3 times 3 times 3. And I just go through and multiply. 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 81. What about 2 to the 7th power? This is 7 factors of 2. So 2 times 2 times 2 times 2 times 2 times 2 times 2. So 7 factors of 2. And I happen to know this is 128 off the top of my head. But again, you can go through it. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. 32 times 2 is 64. 64 times 2 is 128. And like I keep telling you, it's very useful for you to memorize, especially with 2 as the base. Say like 2 squared kind of through, let's say, 2 to the 10th power. They come up pretty often in your exams, and especially when we get the standardized test, you'll see 2 squared, 2 cubed, 2 to the 4th, 2 to the 5th, 2 to the 6th, 2 to the 7th, 2 to the 8th, 2 to the 9th, 2 to the 10th all the time. So it's helpful to memorize those so you can just shoot out the answer right away. What about 15 squared? So this is 15 times 15. And we looked at this in one of the videos. We know the answer already should be 225. Right? But if you didn't know that, you can go through and do a vertical multiplication. Right? 15 times 15. 5 times 5 is 25. 5 times 1 is 5, plus 2 is 7. Then you'd have 1 times 15. You just have to scoot that to the left, right? So I'm going to write 15, a 5, and then a 1. Kind of think about writing it backwards. And then I'm going to add. Bring down the 5. 7 plus 5 is 12. Carry the 1. 1 plus 1 is 2. And of course, I get 225. But I know this from memory, and over time you will as well, because another thing you're going to memorize is you're going to know all from basically 2 squared down through 20 squared. You'll have those memorized by the time you leave 10th grade. You'll know that for sure because it just comes up so frequently. All right, for the last one, we're going to look at 10 to the 6th power. And again, use my trick for this. So you're just going to write a 1 followed by 6 zeros. 1, 2, 3, 4, 5, 6. And so you're going to have 1 million as your answer. And again, use this anytime you have 10 as your base and you have a whole number for the exponent that's larger than 1. So again, 2, 3, 4, 5, 6, 7, 8, anything like that. Anything that's a whole number that's larger than 1, you can use this trick. Hello and welcome to Pre-Algebra Practice Set number 16. And in this video, we're going to look at some additional practice problems for the lesson that we did on the order of operations. Okay, so before we look at any examples, let's just go over the order of operations one more time. Now, the order of operations is something you want to write down, and as you're solving your problems, just kind of refer to it at first. Okay, this is 1, this is 2, this is 3. Go through the steps. After you do enough problems, you won't need that piece of paper anymore. You will just remember it. So the first thing that you always want to do when you work any problem is you want to start off inside of any grouping symbols that you might have. And a lot of people will just say parentheses, but this will include brackets, or you might get a set of curly brackets like that, or whatever you might come across. Any grouping symbols that you have, you need to start out by working inside of those first. So I'm just going to put this as parentheses. Then after you've taken care of what's inside of parentheses, you move on to the next step, which is to take care of any exponent operations you have. So I'm going to write exponents. Then your third step would be multiplication or division. So why do I have this or there? Well, it's because multiplication and division are technically on the same level. They're the same step. So when we come across multiplication and division in the same problem, we work left to right. Okay? We work left to right. And this is a big deal because a lot of students will get this wrong because They'll memorize stuff like PEMDAS, which we talked about in the lesson, right? The please excuse my dear Aunt Sally, and they'll say, well, hey, that M comes before the D, so I must multiply before I divide. No. Multiplication and division, I can't say this enough, are on the same level. You do them left to right. Okay, now the fourth step, or the fourth highest priority, or your lowest priority in any problem, is to add or subtract. Add or subtract. And again, this is on the same level, so we follow this same rule. We do it from left to right. Left to right. Okay? So that's the main thing that you need to remember. This is what trips students up the most. Multiplication and division occur on the same step, left to right. Addition and subtraction occur on the same step, left to right. Okay, let's look at some problems. And we want to evaluate each, and that just means we're going to find the value. So we're going to start with the quantity, 10 minus 6. And I guess I said the quantity because 10 minus 6 is inside of a set of parentheses, then divided by 2. So as you just heard me say, your highest priority in any problem is to work inside of any grouping symbols. In this case, those grouping symbols would be parentheses. So if I look inside the grouping symbols, I have an operation of subtraction. So I want to do 10 minus 6. This is my highest priority in this problem. So 10 minus 6 is 4. So what I'm going to do is I'm going to replace this right here, this 10 minus 6 inside of parentheses, with a 4. And then I'm going to copy the rest of the problem. So divided by 2. And now I have one single operation left, and I just crank that out, and I'm done. 4 divided by 2 is 2, and that's the answer to our problem. We have 8 divided by 4, then times 5. So a perfect example of where you have division and multiplication. And again, where students get confused is they memorize the PEMDAS, right? And you may have seen this, you might have no idea what I'm talking about, but this is kind of a way for you to remember the order of operations. You'd say, please excuse my dear Aunt Sally. Okay, parentheses, exponents, multiplication, division, addition, subtraction. That's what those letters stand for. And because students see multiplication here and division here, they assume that multiplication comes before division. No. These are on the same step, and these are on the same step. They work left to right. So when we see multiplication and division in the same problem, we work left to right. So that means because division occurs first or to the left, we do it before we do the multiplication. So we would do 8 divided by 4 to start. 8 divided by 4 is 2. So we're just going to replace this with this 2, and we copy the rest. And then times 5. And now we have one single operation left. 2 times 5 is 10. And we are done. Okay, now we have 6 minus 1 plus 3. Again, kind of the same situation we came across. We have subtraction and addition. Those are on the same step. We want to work left to right. So because the subtraction occurs to the left of the addition, we do that first. So 6 minus 1 will be our first operation. 6 minus 1 is 5. So I'm going to replace this with a 5. And then I just copy what's left. So plus 3. And one operation left. 5 plus 3 is 8. And we are done. Okay, for the next one we have the quantity, 3 minus 1. Then times 5. Then minus 2. So again, the highest priority would be to work inside of any grouping symbols. And here those grouping symbols are parentheses. So we want to do 3 minus 1 before we do anything else. So 3 minus 1 is 2. So I'm just going to replace this with a 2. Copy the rest of this problem. Times 5 minus 2. And now if we look at the problem, we have multiplication and we have subtraction. So the highest priority here is multiplication. We would do 2 times 5 first. 2 times 5 is 10. So I'm just going to replace this 2 times 5 with a 10. And what's left is minus 2. One final operation, 10 minus 2 is 8. And we are done. Okay, for the next one we have the quantity, 18 minus 6, divided by the quantity, 6 minus 2. So you'll notice that we're going to be working inside the parentheses first in each case, and then we're going to do this division. So in other words, the result of this divided by the result of this. So what is 18 minus 6? 18 minus 6 is 12. So I'm going to replace this with a 12, and then divided by, and then I'm going to copy this, the quantity 6 minus 2. Next, we'll work inside of these parentheses. What is 6 minus 2? That's 4. So I'm going to have 12 divided by, again, the result of this is 4. And one last operation, we just have division, right? 12 divided by 4 is 3. So that is our answer. Okay, let's look at another one. We have 2 times 2 inside of a set of parentheses, then divided by 2. So again, we always work what's inside of parentheses first. So we would do 2 times 2 first, so that's 4. And then we would be dividing by 2. And then we just crank this one out. 4 divided by 2 is 2. And so that's our answer. All right, let's look at one that's a little bit more challenging. Here we have 4 times. Remember, we're implied multiplication here because the 4 is next to a set of parentheses. Inside the parentheses, we have 2 cubed minus, and then another set of parentheses, an inner set of parentheses with 5 plus 1, then plus 1, and then outside these parentheses, we have plus 2. So whenever we work a problem, we always start inside of the parentheses that we have. So you kind of think of this as the first set of parentheses. This is where we look to. But when we get inside of here, we have another set of parentheses involved, right? Because we have multiple operations inside the parentheses. So essentially what we're doing is we're reapplying the order of operations. And that tells us to do parentheses first. So that's why we always say start with the innermost set. So we go to the innermost set, which is right here. So we'll begin with 5 plus 1. 5 plus 1 is 6. So all I'm going to do is I'm going to copy everything, and I'm going to replace the 5 plus 1 that's inside the parentheses with a 6. So 4 times, remember that's times because it's next to the parentheses. And then inside the parentheses we have 2 cubed minus, I'm replacing this with a 6, plus 1. Close the parentheses, then plus 2. Now, we're still working inside of the parentheses now. Okay, we just, so far, just dealt with the innermost set. Now we have to deal with this. So when I look inside the parentheses, I have an exponent, I have subtraction, and I have addition. So I need to deal with that exponent first before I do anything else. So we will have 4 times, and then inside the parentheses, this 2 cubed represents 2 times 2 times 2, right? 3 factors of 2. So 2 times 2 is 4, 4 times 2 is 8. So this will be replaced with an 8, and then I can copy everything else. Minus 6, plus 1, and then close the parentheses, plus 2. Now we're staying inside the parentheses. This is still our highest priority. And basically we just work left to right now because we have subtraction and addition. And so 8 minus 6 will be done first. 8 minus 6 is 2. So we can write this as 4 times, okay, inside of parentheses. The 8 minus 6 is now a 2, then plus 1, close the parentheses, then plus 2. Okay, so now looking at this, we're still not done inside the parentheses. We have one final operation to do. We need to do 2 plus 1. So we'll have 4 times, remember we're implying multiplication because the 4 is next to the set of parentheses. So 4 times the result of this, 2 plus 1 is 3. 3 and then plus 2, plus 2. Okay, so we have 2 operations left. We have multiplication and we have addition. Multiplication is the higher priority. So we're going to do 4 times 3 first. 4 times 3 is 12. And then we have plus 2. And then to finish this off, 12 plus 2 is 14. Okay, now let's look at 4 times, and then we have the quantity 2 plus 3. And then divided by 5 plus, and then we have a quantity 3 minus 1, then times 4. Okay, so again, we want to start inside of any parentheses we may have. So we have parentheses here and here. So let's take care of those first. So we have 4 times, okay, remember this implies multiplication. 2 plus 3 is 5. So I'm going to write this as 5, and then divided by 5, and then plus, inside of parentheses, 3 minus 1, and then times 4. Okay. Next, I'm going to deal with these parentheses here. So 3 minus 1 we know is 2. So I'm going to copy this, 4 times 5, divided by 5, plus, again, 3 minus 1 is 2. This is going to be 2, and then times 4. Times 4. Okay, so now we have multiplication, division, addition, and multiplication. So again, multiplication and division occur on the same step. They're on the same level. We work them left to right. So because this multiplication symbol appears to the left of this division symbol, we're going to multiply first. So what is 4 times 5? 4 times 5 is 20. So I'm going to replace this with a 20. then divided by 5 plus 2 times 4. Next, I'm going to do this division. I do this division first because it occurs to the left of this multiplication. So 20 divided by 5 is 4. So this will be 4, and then plus 2, and then times 4. So now I'm just left with addition and multiplication, and we need to multiply first. So we're going to do 2 times 4 before we do anything else. 2 times 4 is 8. So this will be 4 plus 8, and 4 plus 8 is 12. Okay, so we saved the best for last. So we have 6 divided by, and then inside of brackets, okay, you see these little brackets here, we have 4 minus, and then inside of parentheses, we have 2 squared minus 1, then plus 3 minus, and then inside of parentheses, 6 minus 5. So a lot of grouping symbols involved here. So obviously we want to start inside of the grouping symbols, and brackets are grouping symbols. Very important that you understand that. But once I look inside my kind of outer set of grouping symbols, the brackets, I see that I have parentheses here and I have parentheses here. Okay, so I need to work inside these parentheses first before I can do anything else. So I'm going to start with 2 squared minus 1. So even inside of this right here, this 2 squared minus 1, I have multiple operations. I have an exponent and I have subtraction. I know that I want to do the exponent first. 2 squared is 2 times 2, that's 4. So I'm going to say 6 divided by, and then inside of brackets, 4 minus. The 2 squared is going to be 4 now, so I'm going to put inside of parentheses 4 minus 1, then plus 3 minus, and then inside of parentheses 6 minus 5. Close those brackets. And now I'm going to do 4 minus 1. Okay, now I'm going to work on 4 minus 1. 4 minus 1 is 3. So I'm going to replace that. So 6 divided by, open these brackets, we're going to have 4 minus 3 plus 3 minus, and then inside of parentheses, 6 minus 5. So next we're going to work inside of this set of parentheses. So we have 6 minus 5 in here. 6 minus 5 is 1. So I'm just going to replace that. So we're going to have 6 divided by, open up these brackets, 4 minus 3 plus 3 minus, again, 6 minus 5 is 1. So what's left? Well, we still have grouping symbols, so we still need to stay inside of there. And once we look in there, now we just have subtraction and addition. So when we add and subtract, we go left to right. So essentially, I'm just going to go 6 divided by, and inside the brackets, I would start with 4 minus 3. 4 minus 3 is 1, so I'd have 1 plus 3 minus 1. Okay, so we have 6 divided by, and inside the brackets now, the next thing we're going to do is this addition operation because it's to the left of the subtraction. So 1 plus 3 would be 4. So I'm just going to replace that with a 4, and then minus 1. And then now inside the brackets, we do 4 minus 1, that's 3. So we're left with 6 divided by, and again, inside of here, the result is 3. And so now we finally have one operation left, and that's 6 divided by 3. And of course, that equals 2. Hello and welcome to Pre-Algebra Test Section 1 on the order of operations. Okay, so for the problems we're going to look at today, we just want to evaluate each. And obviously these problems are going to deal with the order of operations. So in case you don't know them, I'm going to briefly cover them real quick, and I'll do that in each video that I do. I want you to write them down as I do, and just use them as you solve your problems. And then after you've solved enough problems, you really won't need them anymore. So your first thing that you're going to do when you work a problem is work inside of any grouping symbols. And generally we just write parentheses for this step. So parentheses. But this would be any grouping symbols you have. You might have brackets, you might have curly brackets, something like that. Any grouping symbols, work inside of those first. The second thing you're going to do is perform any exponent operations. So I'm just going to put exponents. The third thing you're going to do is multiply, or divide. And I've talked about this in the lesson and in the practice set video. This occurs on the same step. You work them left to right. Left to right. And I know this is where a lot of students get confused. They say, oh no, you're supposed to multiply before you divide. That's not true. Multiplication and division occur on the same step. We work them left to right. So whichever one appears to the left of the other, we do that one first. Okay, The fourth step is addition and subtraction. So I'm going to put add or subtract. And this is also a left to right. This is left to right. Okay, so these occur on the same level. And again, we work them left to right. Okay, so go ahead and copy this down. Make sure that you have it. And then we're going to use them to work these problems. All right, so for the first problem, we have 6 times 2 minus 2. So if you think about what operations are involved here, I have multiplication and I have subtraction. So multiplication has a higher priority. If you were to go back and look at that list that I had, and I'll put it back on the screen for a second. If you look at this, you see that you multiply or divide before you think about addition or subtraction. That's why we're going to start this problem by doing 6 times 2. Okay, so 6 times 2 would give us 12. So I just replace this right here with a 12. And then I just kind of copy what's left. I just have a minus 2 left. And now I just have one single operation. I just have 12 minus 2. And 12 minus 2 is 10. So 12 minus 2 equals 10. And now we're done with that problem. Okay, the next problem is 2 plus 5 times 4. So again, 2 operations involved. We have addition and we have multiplication. So multiplication is done before addition. So that means we're going to do 5 times 4 first to begin this problem. So we would have 2 plus the result of 5 times 4. And 5 times 4 is 20. Let me kind of make that a little smaller. So I'm going to put a 20 there. And now I just have one operation. 2 plus 20, and that is 22. Okay, now we have 6 squared minus 1. 6 squared minus 1. So I have an operation with exponents here. I have that squared. And then I have subtraction. So exponents are the highest priority. So I want to do 6 squared first. That's 6 times 6, or 36. So just replace this 6 squared with a 36. And then we're subtracting away 1 from that. And now we just have one operation. 36 minus 1 is just 35. Okay, for the last problem, we have the quantity 9 minus 3 divided by 6 plus 1. So I'm going to always start out inside of any parentheses that I may have. So I have parentheses here. And the operation in there is just 9 minus 3. So 9 minus 3 is 6. So I'm just going to replace this with a 6. And just copy everything else. So divided by 6 plus 1. Now, what I have left is I have division and I have addition. Now, I want to divide before I add because division is a higher priority. So I would do 6 divided by 6 first. 6 divided by 6 is 1. So I'm going to replace this part of this problem with a 1 and then copy what's left. So I just have plus 1 left. And when I go to solve that, it's just 1 plus 1, and that's 2. Hello and welcome to Pre-Algebra Test Section 2 on the order of operations. So for the problems we're going to look at, we just want to evaluate each. And kind of before we start, let me just briefly say a few things about the order of operations. And I know most of you have seen all the videos up to this point, and you want to just jump into the problems. But essentially, the order of operations, again, is a guide to tell us which operations to perform in which order when we have a problem with multiple operations. So, for example, in this first problem, we have 6 divided by 3 plus 2 minus 1. How do we know whether to divide first, to add, to subtract? What do we do? So let me just paste this. This is what I wrote in the last video. And basically, these are your steps. You kind of go through 1, then 2, then 3. It's a level of priorities that you can use to find the answer to your problem. So the first thing you do, your highest priority in any problem is to work inside of any parentheses. Then you want to deal with any exponents. Then you want to multiply or divide. And remember, I keep saying this, that is the same level. You work them left to right. So let me highlight that. So multiplication, division, same level, work them left to right. Then the same for addition and subtraction. Same level, you work them left to right. So meaning if I have 3 times 2 divided by 4, I would multiply before I divide because the multiplication is on the left. If I switch this and I put the division here and the multiplication here, I'm going to now divide first before I multiply because the division is on the left. So that's what we mean when we say work left to right. Whichever occurs on the left is done first. Okay, let me erase all of this. And we begin with a pretty easy problem. So 6 divided by 3 plus 2 minus 1. Again, look at your list and say, well, what's the highest priority here? I have division, I have addition, and I have subtraction. Division is the highest priority, so we would do 6 divided by 3 first. We would do this first. So 6 divided by 3 is 2. So all I'm going to do now is just replace this part of this problem with a 2 and just copy what's left. I have plus 2 minus 1. Now I have addition and subtraction. Those occur on the same level, so they have the same priority. But we work them left to right, so we kind of think about it going this way. Which occurs first? Well, the addition does. So that's why I'm going to do 2 plus 2 first before I think about the subtraction. So 2 plus 2 is 4. So I'm going to write a 4 down there, and then we're subtracting away 1 now. So now I have 4 minus 1, single operation, 4 minus 1 is 3, and we're done. Okay, now we have the quantity 5 plus 3. So when I say the quantity, that's because 5 plus 3 is inside of parentheses. Then we're multiplying by 3, and then we're adding 3. So what's our highest priority here? Well, we always look for parentheses or any grouping symbols whenever we start a problem. So the highest priority would be to work the operations inside of the parentheses, okay? Inside of the parentheses. So what is 5 plus 3? That's 8. So I would just replace this with an 8 and copy what's left. So times 3 plus 3. So now I have multiplication and I have addition. Okay, so I want to do multiplication before addition. It's a higher priority. So I would do 8 times 3 first. That's 24. And then we're adding 3, so plus 3. One operation left. 24 plus 3 is just 27. Okay, let's look at 5 times, and then we have 4 times 2 inside of a set of parentheses, and then divided by, and then we have 1 plus 3 inside of a set of parentheses. Again, the highest priority when you work a problem is looking at what's inside of parentheses first. Okay? So when we think about this, we would do 4 times 2. 4 times 2, that's 8. So I can write 5 times 8, and then divided by, and then 1 plus 3, this quantity, right? It's inside of parentheses. So we have these parentheses left. We still have to deal with those first before we can do anything left. So we'd have 5 times 8 divided by, I just copied this part, the result of this. 1 plus 3 is 4. So now we have multiplication and division only. Again, those have the same level of priority. We work them left to right. So going this way. Now, what occurs to the left? The multiplication does, right? So we're going to do that first. So 5 times 8 would give us 40. And then we're dividing by 4. So divided by 4. One operation left. 40 divided by 4 is 10. Okay, let's take a look at the last one. We have 5 squared minus, and then inside of parentheses, 6 divided by 3 plus 5. So again, whenever we work a problem, we want to start out by looking at, hey, do we have any parentheses or grouping symbols? And then we want to start inside of there. But if you look inside the parentheses, we actually face another problem because we have division and we have addition. So when you get inside of the set of parentheses or the brackets or whatever the grouping symbols are, you need to reapply the order of operations. So you just say, okay, this is my problem now, and what's the highest priority? Well, division is a higher priority than addition. So we do the division first. So I would do 6 divided by 3 before I think about adding anything. So 6 divided by 3 is 2. So I'm going to do 5 squared minus, and then the result of 6 divided by 3 again is 2. And then we'll have this plus 5. Okay, and so now we're going to continue inside the parentheses there. Inside the parentheses, we have 2 plus 5 now. So 2 plus 5 is 7. So we'd have 5 squared minus, again, this is 7. And now when we look at our problem, we have 2 operations left. We have this exponent here that we have to deal with, and we have the subtraction. So exponents are your next highest priority after you deal with parentheses. So 5 squared would be 5 times 5, that's 25. And then we'd be just subtracting away 7. So to finish this problem off, 25 minus 7 gives us 18. Hello and welcome to Pre-Algebra Test Section 3 on the order of operations. Okay, so for the problems we're going to look at, we just want to evaluate each. And before I kind of start with the first problem, let's just take a look at kind of the order of operations. And this is kind of handwritten, but I want you to write these down if you don't already have them written down and use it as we're solving the problems. As you work more and more problems, you'll get more and more comfortable with this, and eventually you'll have it memorized and you won't need to use it at all. Basically, the first thing that you want to do when you have a problem with multiple operations is work inside of any parentheses. And when I say parentheses, we also want to include in that brackets. So basically any grouping symbols that you come across, you need to work inside of those first. The next thing you want to do, or your next highest priority, would be to perform any operations involving exponents. Then when you're done with that, you want to look at multiplication and division. Now, multiplication and division occur on the same step, so they have the same level of priority. So what do we do if we have multiplication and division in the same problem? We work left to right. We work left to right. So whatever occurs to the left of the other is what we do first, okay? And the same thing goes for addition and subtraction. They have the same priority level, but again, we're going to work them left to right. So now let's look at the first problem. All right, so we're going to begin with 4 squared minus the quantity, 3 plus 6, minus the quantity, 4 minus 2, then plus 2. So we always want to start by working inside of any grouping symbols that we have. So we have parentheses here, and we have parentheses here. So we basically want to work inside of those before we do anything else, okay? So I'm going to copy 4 squared minus, what is 3 plus 6? We're doing that first. 3 plus 6 is 9. So I'm going to replace this with a 9. Then I'm just going to copy what's left. So minus, we have this quantity 4 minus 2, then plus 2. I'm not done with the parentheses. I still have this 4 minus 2 to deal with inside of parentheses. So let's do that. 4 minus 2 is 2. So let's copy this problem down as 4 squared minus 9 minus, again, the result of this is 2, then plus 2. Now if I look at what's left, I just have an exponent, subtraction, and addition. So addition and subtraction occur on the same level, but they're a lower priority than doing 4 squared, right? We want to do anything with exponents first. So 4 squared is 16, right? It's 2 factors of 4. It's 4 times 4. It's 16. So 16, and then minus 9, minus 2, plus 2. So just subtraction and addition. These have the same level of priority. We work them left to right. So kind of the first operation, or the leftmost operation, would be 16 minus 9, and that gives us 7. So I'm going to replace this with a 7, and then we have minus 2 plus 2. And let's just scroll down a little bit, get a little room going. And kind of the next thing we're going to do, we have 7 minus 2 plus 2. This is your leftmost operation, so we're going to do 7 minus 2. That's 5, and then plus 2. And then one final operation, 5 plus 2 is 7. Okay, the next one's a little challenging. It's actually a little challenging to read through too. So we have 3 times, remember when you have a 3 next to the parentheses there, that's telling us we have 3 times the result of the parentheses. Now, when you have multiple parentheses involved, like you do in this problem, it kind of helps to take and say, okay, where are the parentheses for? So this first set of parentheses that you come across is enclosing all of this. All of this is enclosed in that first set, okay? Let me erase that. Then once you get inside of there, you have more parentheses involved. Next, you have 3 times. Now we're going to come across another set of parentheses, and that's going to enclose this other set of parentheses with 10 minus 6. So you can say the quantity 10 minus 6 times 2. Okay, so let me highlight kind of this last set of parentheses here. So we always start, when we have parentheses, with the innermost set. And the reason for that is, once you get inside of your parentheses, you reapply the order of operations. So in other words, once we got inside of the highlighted in yellow parentheses, we looked for the highest operation. That was another set of parentheses, the ones that are highlighted in blue. Then once we got inside of there, we looked for the highest priority, which was another set of parentheses, the ones that are highlighted in green now. So we start with this innermost set, which contains 10 minus 6. And we're just going to replace 10 minus 6 with 4, right? 10 minus 6 equals 4. So we're going to copy this problem down, and the only thing we're going to change is that quantity 10 minus 6, we're going to put a 4 there. So 3, and then this will be a 4. And then we still have this times 2. Close that. Divided by 4 plus 4, and then close that. Okay. So now when we look at this problem, we still have an outer set of parentheses, and we still have an inner set of parentheses. So in other words, when you look at the outer set, you would reapply the order of operations once you got inside, and you'd look for parentheses again, and you find them right there. So we would do 4 times 2 before we tackle anything else. Okay? 4 times 2 before we tackle anything else. 4 times 2 is 8. So I'm going to put 3, and then we have parentheses, we have 3. 4 times 2 is 8. We know that, so I'm going to replace this with times 8. And again, the reason I said times 8 is because this 3 is standing outside of a set of parentheses that implies multiplication. So 3 times the result of this, 4 times 2, which was 8. Okay? Then divided by 4 plus 4. Now it's starting to look pretty easy because we just have one set of parentheses. And when we look inside of the parentheses, now we have multiplication, division, and addition. Pretty simple. So we know that multiplication and division are a higher priority than addition. And we know that multiplication and division occur on the same priority level. Okay? But we work them left to right. Left to right. So this operation, this multiplication, occurs to the left of this division operation. So we are going to multiply first before we do anything else. So 3 times 8 gives me 24. So I'm going to have 3, and then inside of parentheses, again, 3 times 8 is 24. And then we copy the rest. Divided by 4 plus 4, and close that off. Okay. Scroll down, get a little room going. Now, the next step, we're still inside these parentheses. We have division and we have addition. So we know we want to divide first. That's the highest priority. So 24 divided by 4 is 6. So this will be 3 times, and now this will be the quantity 6 plus 4. All right, all I did was replace this with a 6. Now we're still inside the parentheses. So 6 plus 4 would give us 10. So I would have 3 times 10. So I could write it like this, right, if I wanted to. Or I can just write it the traditional way and put 3 times 10 like that. Doesn't really matter. Again, when you have that 3 outside of the set of parentheses, it implies multiplication. So let's finish this up. 3 times 10 is 30. Hello and welcome to Pre-Algebra Test Section 4 on the order of operations. So before we kind of get into our problem, let's just go over the order of operations real quick, just so that we're on the same page. Now, when you first start working with the order of operations, you want to write down the steps and then use that when you solve your problems. Eventually, after you work enough problems, you'll have it memorized. But for right now, make sure that you have it written down so that you can refer to it as you're working through your problems. So when we look at a problem that has multiple operations in it, we use the order of operations to tell us which operation to perform in which order. So kind of the first thing, or your highest priority, is to always look for parentheses or any grouping symbols like brackets that you might have in your problem. The next thing you want to do is perform any exponent operations. Okay, so that's your next highest priority. Then after that, you get into multiplication and division. And this one causes a lot of confusion among students. Multiplication and division have the same level of priority. When you have multiplication and division in a problem, when you have both of them, you want to work from left to right. Okay, you want to work from left to right. So that means if you had something like 5 times 3 divided by 7, you would do the multiplication first before the division because you're working left to right. Starting left, going to the right. If I flip the order of that and put the division symbol here, the multiplication symbol there, now you're going to divide first, right? Again, we're working left to right. So the same thing happens when you get to addition and subtraction. So after we've taken care of the multiplication and division, our lowest priority is addition or subtraction. So for addition and subtraction, it's the same level of priority. We work left to right. So in other words, if I had 5 plus 3 minus 7, I would do the addition first because it's on the left, and the subtraction last. If I flip that and put the minus here and the plus here, now the minus sign occurs to the left of the addition, so we would do the minus first. We would do 5 minus 3 first. Okay, now I think we're ready to look at our problem. So we just want to evaluate each, and we're just going to have one problem here. So we have this quantity, 3 plus 2, and it's squared, right? It's raised to the second power. Then we're subtracting away, and notice how you're going to have two sets of parentheses here. You have 10 squared divided by this quantity 6 plus 4, then minus 8, okay? Now, when we start working a problem, we're always looking for parentheses or any grouping symbols first. So let's look over here. We have a set of parentheses that we're going to work with first. We'll deal with this in a second. So I have 3 plus 2 inside of a set of parentheses. 3 plus 2 is 5. So I'm going to replace this with a 5, and now it's squared. And let me just copy the rest of this problem. Okay, now looking at this problem again, we need to reassess what's the highest priority. So I have parentheses. And I always want to work inside of those to start. Now, once I get inside of the parentheses, I reapply the order of operations, right? Because I have an exponent here, I have division, I have parentheses, I have a subtraction. What do? Well, I always go for parentheses first. So I start at the innermost set of parentheses. That's why they say that. Because once you get inside of the parentheses, you look for parentheses again. So that's what we have here. So we would do 6 plus 4 before we do anything else. 6 plus 4 is 10. So I'm just going to replace that with a 10. So 5 squared minus, let's copy the rest of this, 10 squared divided by, we're replacing the 6 plus 4 with a 10, minus 8. And now we're still working inside of the parentheses. We're still inside of this guy. We need to think about what's the highest priority. I have an exponent, I have division, and I have subtraction. So I need to take care of that exponent first. 10 squared is 100. Okay, 10 squared is 100. So 5 squared minus, the 10 squared will be 100, divided by 10 minus 8. We're still working inside of the parentheses. Now I have division and subtraction. Division is the higher priority, so we would do 100 divided by 10 next. So 5 squared minus, and then inside of the parentheses, again, 100 divided by 10 is 10, then minus 8. And one final operation to do inside the parentheses here. We just want to do 10 minus 8, and that's 2. So now we have 5 squared minus, again, this is 2. And so we're down to just two operations. We have this exponent and we have subtraction. So we know that the exponent has the higher priority. So we do 5 squared. 5 squared is 5 times 5, that's 25. So 25 minus 2. And one final operation that gives us 23 for our answer. Hello and welcome to Pre-Algebra Test Section 5 on the order of operations. Okay, so before we look at the problem, let's just cover the order of operations one last time. So when we look at the order of operations, again, this is something that gives us a guide to solve a problem with multiple operations in it. What do we do in what order? Well, this answers that for us. So the first thing we're going to do is work inside of any parentheses or grouping symbols like brackets that you may come across. Then the next thing you're going to do is perform any operations that involve exponents. Then after that, we have multiplication or division. Okay, so multiply or divide. Now, this is kind of confusing for people. This multiplication and division, this step right here, multiplication and division have the same level of priority. When you work through a problem where multiplication and division is involved, you work left to right. So if you have a problem like 10 divided by 2 times 6, you do your division before your multiplication because you're working left to right. You start on the left, the division occurs first before the multiplication. If this order was flipped and I put the multiplication symbol here, the division symbol there, well, now I'm going to multiply first, right? Because I'm working left to right. So you need to understand that. You need to write that down and put an asterisk next to it and say, hey, this is the same level of priority. We work left to right. The same thing goes when you get to addition and subtraction. It's your lowest priority, but it's the same level of priority. So addition and subtraction are the same level of priority. We work them left to right. So if I have 5 plus 7 minus 2, I would add first, working left to right. Start on the left, go to the right. if I have the minus sign over here and the plus sign over here, now I'm subtracting first, right? I'm subtracting first. Now let's take a look at our problem. So we want to evaluate each, and we just have one problem to work through. And it's going to be 8 times 12 divided by 3 times 2 plus 4 cubed plus 10 minus 11. So no parentheses involved, so immediately we can eliminate that step. And we look for any exponents. And we have this one right here. We have 4 to the third power, otherwise known as 4 cubed. So what I'm going to do is just copy everything. 8 times 12 divided by 3 times 2 plus 4 cubed. So I'm going to start with that. So 4 cubed is 4 times 4 times 4. 4 times 4 is 16. 16 times 4 is 64. So I just replace that with the 64, and I just keep copying the rest of the problem. Okay. Now I'm looking for the next highest priority. I have multiplication, division, multiplication, addition, addition, subtraction. So the highest priority would be to multiply or divide, and again we do this left to right. So I see that I have multiplication here all the way to the left, and it's to the left of this division. So I'm going to do that first. So what is 8 times 12? Well, that's going to be 96. Okay, that's going to be 96. And then divided by 3 times 2 plus 64 plus 10 minus 11. Now we still have division and multiplication as the highest priority, right? That comes before addition or subtraction. And again, we're working left to right. So now this division comes before this multiplication. So that's what we're going to do next. So we're going to do 96 divided by 3, and that's going to give us 32. Okay, that's going to give us 32. So then times 2 plus 64 plus 10 minus 11. So now we have multiplication, addition, and subtraction. We want to multiply first. So 32 times 2 is 64. So 64, then plus 64, then plus 10, then minus 11. Okay, now we just have addition and subtraction. And we basically just work left to right. So start all the way on the left, and 64 plus 64 is 128. 128, then plus 10, then minus 11. Then 128 plus 10 is going to be 138, then minus 11. And we'll finish this off with 138 minus 11, and that's 127. Hello and welcome to Pre-Algebra Practice Set 17. In this video, we're going to look at some additional practice problems for our lesson on the introduction to integers. So for the first few problems, we want to replace each question mark with the inequality symbol less than or greater than. So we begin with -2 question mark -4. So again, as I told you in the lesson, kind of the way you think about negatives, as you get bigger negatives, you're actually getting smaller numbers. Remember that if a number lies to the left of another number on the number line, it's actually a smaller number. So the numbers are decreasing this way. And again, you can also think about it, numbers increase this way. So if a number is to the right of another number on the number line, it's a bigger number. So when we think about -2 and -4, so -2 is here, -4 is here. -4 is to the left of -2 on the number line, so it's a smaller number. So we have -2 and we have -4. So remember, we want to use the inequality symbol that points to the smaller number. Again, -4 is smaller. It's to the left of -2. So we're going to use the greater than symbol because that's the one that's going to point to -4. So -2 is greater than -4. What about -5 question mark 0? So here's 0 on the number line. Here's -5. -5 is to the left of 0 on the number line, so it's a smaller number. Or you could have also said 0 is to the right of -5 on the number line, so it's a bigger number. Again, we want the symbol to point to the smaller number. So I'm going to use the less than symbol because that's going to point to the -5. So -5 is less than 0. Okay, let's take a look at -10 question mark -20. So we don't have a number line here. We're just going to reason our way through this. If we had the numbers 10 and 20, let's think about their relationship. 10 is a smaller number. If I have $10 in my pocket, I have less money than if I have 20. So we would say 10 is less than 20 like that. But if these numbers were negative, the reverse would be true. So -10 would not be less than -20. It would actually be greater than. -10 represents a smaller negative, and therefore it is more than negative 20. As these negatives get bigger and bigger, you're getting smaller numbers. We're going to the left on the number line that way. And you can also think about this using money. If I owe $20, I'm worse off than if I only owe 10. Right? I'm worse off in this scenario. Okay, now we want to find the opposite of each number. And recall, to find the opposite or the additive inverse of a number, you just change the sign. That's all we're going to do here. So we're going to start out with negative 5. The opposite of negative 5 would be positive 5. So I just write 5. Then we have 7. The opposite of 7 would be negative 7. Then we have negative 12. The opposite of negative 12 would be positive 12. Then we have 55. The opposite of 55 would be negative 55. Again, all we're doing is just changing the sign. Okay, now we want to simplify. And essentially what we do when we have problems like this, we're just using our knowledge of taking the opposite of a number, but we're applying it without actually asking that question. We're using symbols to say, hey, what is the opposite? What is the opposite of whatever's inside the parentheses? And in this case, it's negative 12. So if I asked you, what is the opposite of negative 12? You would reply 12. So that's all this is doing. It's just saying, hey, change the sign of whatever's inside the parentheses. Okay, now we have the opposite of negative 18. And in the lesson, I showed you a trick. When you start getting a lot of these symbols in a row, you can count how many symbols you have. So even though this is the opposite of negative 18, or you could say the negative of negative 18, however you want to think about it, you have 3 of these symbols. 3 is an odd number. Again, it's a number that's not divisible by 2, so we know the result will be negative. So this would be negative 18. You can kind of reason your way through this. Each time you have a pair of negatives, you end up with a positive. So the opposite of negative 18 would give you positive 18. Then when you get to this negative, positive 18 becomes negative again, and you have no more negatives out there to pair with that to make it positive. So an odd number of negatives will yield a negative result. Okay, here we have the opposite of, and then inside of parentheses we have 9 minus 7. So all this is telling me to do is, hey, do the operation 9 minus 7 first, and then when you're done, take the opposite of it. So 9 minus 7 is 2, and then the opposite of that is negative 2. Okay, now we have one of those ridiculously long ones. So we have the opposite of, 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 the opposite of negative 37. Okay, so how many do we have? We have 1, 2, 3, 4, 5, 6, 7, 8. 8 is an even number. It's divisible by 2. 8 divided by 2 is 4, no remainder. So I know that the result here will be positive. So this is going to be positive 37. And you can kind of think about this using pairs of negatives. So this would become positive, 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 and then positive, right? If I go from here to here, it becomes positive. Here to here, it becomes negative, but then positive again. Here it becomes negative, but then positive. Negative, and then finally positive. So each pair of negatives makes a positive. So when we have 1, 2, 3, 4 of those pairs and nothing left over, we get a positive result, right? If I added another negative out there, you would have 9 of them, and you'd basically have 4 pairs and then kind of 1 left over that you can't make into a pair. Again, an odd number of these, so you get a negative result. Hello and welcome to Pre-Algebra Test Section 1 on the Introduction to Integers. Okay, so for the problems in this video, we want to just replace the question mark with the inequality symbol less than or greater than. So we start out with a -1 question mark -2. So when we look at the negatives here, we see that -1 is here, and we see that -2 is here. So remember, as you move left on the number line, the numbers are getting smaller. And when we work with negatives, at first it seems a little confusing because we're used to 2 being bigger than 1. But because they're negative, bigger negatives mean smaller numbers. So what happens is -2 is a bigger negative, is to the left of -1 on the number line, so it's a smaller number. So we would have -1 and -2 here. And remember, we're going to use the symbol that points to the smaller number, so we're going to use the greater than, because the greater than would point to -2, and again, that's the smaller number. So -1 is greater than -2. What about -4 question mark 0? So -4 is here, and 0 is here. -4 is to the left of 0 on the number line, So it is the smaller number. And again, without using a number line, you can kind of just reason through this. If I have $0 in my wallet, meaning I have no money, I am better off, I have more than if I owe $4, right? -4 could be used to represent a debt of $4. So -4 is the smaller number. So we're going to point the symbol towards -4. So we're going to be using a less than. -4 is less than 0. All right, here we have 2 question mark -2. So 2 is here and -2 is here. This one's really easy even without using a number line because you know if you have $2, it's more than if you owed $2. So 2 is clearly the bigger number. And again, you can see that by looking at the fact that 2 is to the right of -2. So you could say it's bigger. Or kind of flipping that around, you could say, okay, well, -2 is to the left of 2, so you know that it's smaller. So we have 2 and -2. Remember, the symbol is going to point to the smaller number. So it's going to point to the -2. So I want to use a greater than. So 2 is greater than -2. We have -90 question mark -20. So I want to think about this in terms of, let's make these numbers positive. Let's pretend we have 90 and we have 20. What's the relationship between these numbers? Well, it's easy to say that 90 is greater than 20, right? If I have $90 in my wallet, I have a lot more than if I only have 20. If I flip this around and say, okay, well, now I'm working with negatives, it's no longer true. And I wouldn't say that -90 is greater than -20. That's not true. I'd have to flip this around. -90 would now be the smaller number because it's a bigger negative, right? It's a bigger negative. -90 would be less than -20. Again, think about this in terms of money. If I owe $20, I am better off than if I owe $90, okay? I am better off than if I owe $90. And if you think about kind of visualizing this on a number line, we don't need to go through and make, a number line other than, let's do like a simple one with 0 here. I don't know, let's say -20 is here. We know -90 is to the left, right? Because we would count this way. So -90 could be somewhere over here. It's to the left of -20. It's a bigger negative, and therefore it's a smaller number. So -90 is less than -20. Hello, and welcome to Pre-Algebra Test Section 2 on the Introduction to Integers. Okay, so for the problems that we're going to look at in this video, we want to replace the question mark with the inequality symbol less than or greater than. So we're going to begin with -6 question mark -3. So if we look on our number line, we see that -6 is here and -3 is here. So what do we know about the number line and the relationship between numbers? We know as we move to the left, numbers get smaller. So meaning that if -6 is to the left of -3 on the number line, it is a smaller number. And this may be a little counterintuitive for you at first because you're used to 6 being bigger than 3. But when we think about negative numbers, the bigger a negative is, the smaller it actually is. So -6 is less than -3. And again, I'm using the less than there because I want the symbol that's going to point to the smaller number, and -6 is the smaller number in this case. What about 0 question mark -1? So looking at the number line, 0 is here, -1 is here. -1 is to the left of 0 on the number line, so it's a smaller number. Or you could say 0 is to the right of -1 on the number line, so it's a bigger number. So you have 0 and you have -1. And again, you want to point the symbol to the smaller number. So that means I'm going to use a greater than because I want to point the symbol towards the -1. So 0 is greater than -1. Okay, what about -2 question mark -18? So we have a number line here, but we don't see -18 there. We see -2 here. But you can kind of use this to think, okay, well, this is decreasing in increments of 1. So you'd have -9, then -10, then -11. -18 would be this way, right? It would lie to the left of -2 on the number line. That's all the information we actually need. -18 is a bigger negative, and so it's a smaller number. So we would have -2 is greater than -18. Again, use the symbol that's going to point to the smaller number. In this case, the smaller number is -18. All right, for the last one, we don't have a number line. We have -615 question mark -2000. So again, use your reasoning. If you owe $615, you owe less than if you owe $2,000. So this is a bigger number. the negative 615. The negative 2000 is a smaller number. So I want to point the symbol to the smaller number, and I would use a greater than. So negative 615 is greater than negative 2000. Again, as negative numbers get bigger, they represent smaller values. So this one is actually smaller than this one. Hello and welcome to Pre-Algebra Test Section 3 on the Introduction to Integers. Okay, so for our problems, we're going to do something very, very easy. We just want to find the opposite of each number. So to find the opposite of a number, you just change the sign of the number. So for example, where we start out here with 12. If I want to ask, what is the opposite of 12? It's just negative 12, right? It goes from positive to negative. What is the opposite of 9? Well, it's just negative 9. I change the sign from positive to negative. What is the opposite of negative 4? Well, I change the sign from negative to positive, so this would just be 4. What is the opposite of negative 1? Well, I change the sign from negative to positive, so it would just be 1. What is the opposite of 1045? I change the sign from positive to negative, so I'd have negative 1045. Now, what is the opposite of 87? So again, I just change the sign. So from positive to negative. So the opposite of 87 is negative 87. And then for the last one, what is the opposite of negative 132? It's just 132. Hello and welcome to Pre-Algebra Test Section 4 on the Introduction to Integers. So for the problems we're going to look at, we just want to simplify. And we're going to start out with the opposite of negative 7. Or you could say the negative of negative 7, however you want to think about that. Essentially what this symbol right here, this negative symbol is telling you is you want to change the sign of whatever's inside the parentheses. So I have a negative 7 inside the parentheses. So hey, change the sign of that. It would become positive 7. So again, the opposite of negative 7 would be 7. Okay, so now we have the opposite, or we could say the negative of, and then inside of parentheses we have 4 plus 7 times 2. So when you get a problem like this, just think back to your order of operations. You want to work inside the parentheses first. So we'll kind of leave this negative for last. So if I look inside the parentheses here, I see that I have addition and multiplication. We know from our order of operations lesson that multiplication is the higher priority. So we would do 7 times 2 first. So 7 times 2 is 14. So I'm just going to replace that with a 14. So we'd have 4 plus 14. If I perform that operation, I would get 18, right? 4 plus 14 is 18. So I'd have my negative symbol out in front and then an 18 inside of the parentheses. And now I just have a negative that's hanging out in front of a set of parentheses. It's basically just saying, hey, find the opposite of whatever's inside the parentheses. So what is the opposite of 18? Well, it's just negative 18. Okay, now we have a problem that can be kind of tedious if you don't use the shortcut that I covered in the lesson. So we have the opposite of, the opposite of, the opposite of, the opposite of negative 29. So kind of the shortcut is to look through and see how many of these symbols you have. So I count 1, 2, 3, 4, 5 of them. 5 is an odd number, right? It's not divisible by 2. 5 divided by 2 is 2 with a remainder of 1. So what happens is you end up with a negative result. So you would end up with negative 29. Now, kind of reasoning your way through this, each pair of negatives would make a positive. So there I have 2 pairs, or kind of a total of 4 signs. And when you get out to this one right here, you would end up with a negative and nothing to pair with it to make it positive again. So you can think about it that way. You can do this the long way. You can start inside with negative 29 and kind of work your way outside. So this guy right here would make this positive. Then this would make it negative, then positive, and then negative for the final answer. So we end up with negative 29 as a result. Okay, now we have the opposite of, the opposite of, the opposite of, the opposite of, and then inside of parentheses, 13 minus 7. So for this one, we want to just do the operation inside of the parentheses first. And then when we're done, we can use our shortcut. We have 1, 2, 3, 4 of these guys. 4 is an even number, right? 4 divided by 2 is 2, no remainder. And so if you get an even number of these signs, you're going to end up with a positive result. So I know what's inside of the parentheses is 6. So once I apply that shortcut, I would just have positive 6. Okay, now if we wanted to do this the slow way, we can kind of start by just doing this operation in here. So let me just copy all this again. The opposite of, the opposite of, the opposite of, the opposite of, and then inside the parentheses we'd replace that with a 6. And now we could work our way outward. So this would become negative, then positive, then negative, and then finally positive. So again, either way you do it, you end up with positive 6 as your answer. Hello and welcome to Pre-Algebra Test Section 5 on the Introduction to Integers. Okay, so for the problems in this video, we just want to simplify. We're going to start out with the opposite of negative 912. So as you'll recall in the lesson, I gave you a little shortcut for solving a problem like this. All you need to do is count the number of negative symbols that you see in the problem, and then if the number is odd, the result is negative. If the number is even, the result is positive. Here you have 3 of them. You have 1, 2, 3. That's an odd number, and so the result would be negative. So I could just write negative 912 and be done. Now, kind of the slower way to do this would be to start at the innermost set of parentheses. So start with a negative 912, and you'll work your way outward. So in other words, you would go out here and say, okay, well, this is the opposite of negative 912. So that makes it positive. And then we would do that one more time. We would say, okay, I want the opposite of the result of what we just found, which was positive 912. That would change the sign again. It would become negative 912. Okay, now we have the opposite of 4 squared minus 15. So what we'd need to do is actually figure out what 4 squared minus 15 is first, and then we can use our little trick. So 4 squared would be done first because of the order of operations. We do exponents before subtraction. 4 squared is 4 times 4, that's 16. So I'm going to rewrite this with the opposite of, and then we'd have 16 minus 15. Now, next, we're still working inside those parentheses. We have 16 minus 15. That's going to give us 1. So we'd have the opposite of the number 1. And now we can just count the number of these symbols that we have. We have 1, 2 of them. 2 is an even number, so the result would be positive. And alternatively, you could have just said, okay, well, I want the opposite of 1. That's going to be negative 1. And then I want the opposite of negative 1. That's going to give me positive 1. And some of you might be saying, well, how come I didn't include this symbol in here? Well, this is subtraction, right? When you have an operation that you're doing inside the parentheses there, just do the operation first. And then once you have a single number left, you can use that little trick. Okay, now we have one that's fairly ridiculous, and you might get this on your test, so it's good to practice. We have the opposite of, 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 the opposite of negative 1037. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 is an odd number, so this will be negative. This will be negative 1037. And I'm not going to do it, but you can go and work backwards if you want. You can start inside the parentheses here with negative 1037 and go, okay, well, this would make it positive, then negative, then positive, so on and so forth till you get all the way down there, and you would see that you would end up with a negative. Hello and welcome to Pre-Algebra Practice Set number 18. In this video, we're going to look at some additional practice problems for our lesson on absolute value. Okay, so we want to find the absolute value, and we're going to start out with the absolute value of negative 7. So as I told you in the lesson, to find the absolute value of a number, it's very, very simple. If the number is negative, just make it positive. If the number is 0 or positive, it's just that number. So if I want to find the absolute value of negative 7, since it's negative, I just make it positive. So just kind of think about, okay, it's negative 7, now it's positive 7. And that's it. That's all there is to it. So what is the absolute value of negative 12? Again, it's a negative number, so just make it positive. So the absolute value of negative 12 will just be 12. What is the absolute value of 35? Well, now we have a positive number, and essentially if you have a positive number, it's just that number. So the absolute value of 35 is 35. Here's one that trips people up a lot. What is the absolute value of 0? And I did it twice in the lesson just to make sure that you knew that the absolute value of 0 is 0. And again, the reason for this is if you look on a number line, kind of with the basic definition, if I ask you for the absolute value of 1, it's 1 because it's 1 unit away from 0 on the number line. If I ask you for the absolute value of 0, it's 0 because 0 is 0 units away from 0 on the number line, right? It's no units away from itself on the number line. So the answer there is just 0. What about the absolute value of negative 715? Again, we have a negative number, so just make it positive. So the answer would be positive 715. And then for the last one, what is the absolute value of negative 2,212,513. Well, again, it's a negative number, so we're just going to make it positive. So it would be positive 2,212,513. All right, now we're going to look at some different problems. We want to replace the question mark with less than, greater than, or equal to. So we start out with the absolute value of negative 92, question mark, the absolute value of 53. So which one of these guys is going to be bigger and which one is going to be smaller? Well, when we think about absolute value, remember, we're not going to have any negatives involved. So I can go through and think about negative 92 here. Because it's a negative and I'm taking the absolute value, it's going to become positive. So this would be positive 92. 53 is a positive number, so it's just going to stay the same. So when I compare 92 and 53, I know 92 is a bigger number, so I would use a greater than symbol here. Right? I want to point the symbol to the smaller number, so I would say the absolute value of negative 92, which is 92, is greater than the absolute value of 53, which again is 53. What about the absolute value of negative 15, question mark, the absolute value of 15? Well, once we take the absolute value here, we're going to see that we have the same number, right? Because the absolute value of negative 15 is 15. The absolute value of 15 is 15. Remember, if you have opposites, which in this case is negative 15 and 15, they're opposites, they have the exact same absolute value. So we'd use an equal sign here. So the absolute value of negative 15 is going to be equal to the absolute value of positive 15. Okay, what about the absolute value of 0, question mark, the absolute value of negative 34? Well, the absolute value of 0 is 0. The absolute value of negative 34, again, is just going to be 34. Right? For a negative, you just make it positive. So the absolute value of 0 is going to be smaller or less than the absolute value of negative 34. Again, always point that symbol to the smaller number. In this case, the smaller number is 0. Okay, we have the absolute value of negative 81, question mark, and then we have the absolute value of 85 minus 4. So the absolute value of negative 81 is 81, right? If it's negative, just make it positive. And then 85 minus 4 is 81, and if we took the absolute value of that, we would get 81 as well. So these two values will be equal. So the absolute value of negative 81 is equal to the absolute value of 85 minus 4. In each case, once you go through the operations that are involved, you would have a value of 81, right? So those two are equal. Okay, now we're just going to simplify. And so we're going to start out with the opposite of, and then we have the absolute value of negative 17. Now, I warned you about this in the lesson. You have problems where you'll see the opposite of negative 17 like this. No absolute value bars involved. What I've told you is the shortcut is you can count the number of these symbols you have, the number of negatives. If it's even, it's going to be a positive number. If it's odd, it's going to be a negative number. So here you have two of those symbols. 2's even, so you get positive 17. In this case, you will not get a positive 17. You might go through and say, okay, I have 1, 2 of these symbols and positive 17. No, that's wrong. And here's the reason. When you have the absolute value operation involved, remember, the result of this guy right here is always going to be non-negative, meaning it's 0 or larger. So you can't ever count the negative that's inside of the absolute value operation because it's going to make it into a positive number. So what we have to do is just count the ones that are outside. So if I just count here, I have 1 that's outside, 1's an odd number, so this would end up being negative 17. Going through this the slow way, you can just evaluate. The absolute value of negative 17 is 17, so I would have the negative of, or the opposite of, 17, and then I would just change the sign. So it would go from positive 17 to negative 17, and that would be my answer. Okay, here we have the opposite of, and then inside of the absolute value operation, we have 5 plus and then 7 squared. Okay, so the opposite of, the absolute value of, 5 plus 7 squared. Inside of these absolute value bars is where we would start. And remember the order of operations. If you have addition and you have an exponent, you do the exponent first. So 7 squared is 7 times 7. I think we all know at this point that's 49. So I would write this as the opposite of, the absolute value of, 5 plus 49. Now we can do our addition. 5 plus 49 is 54. So this would be the opposite of the absolute value of 54. And then the absolute value of 54 is just 54, right? If it's a positive number, it's just itself. So we'd have the opposite of 54. And then we just take the opposite of 54 and we end up with negative 54 as our answer. Now we have the opposite of, the opposite of, the opposite of, and then inside of absolute value bars, 35 minus 2 squared. So I'm going to think about what's in the absolute value bars first. Okay, what's in the absolute value bars first? And then if I look outward, I know I have 1, 2, 3 symbols that are going to be involved. 3 is an odd number. So I know in the end it's going to be a negative result. But I got to find out what the value is for inside the absolute value bars first. So if I look in here, I have 2 operations. I have subtraction and an exponent. So I know I want to do the exponent first. So the opposite of, the opposite of, the opposite of, and then inside the absolute value bars, we're going to have 35 minus 2 squared is 2 times 2, that's 4. So minus 4. And so now working inside the absolute value operation, 35 minus 4 is 31. So we'd have the opposite of, the opposite of, the opposite of, and then the absolute value of 31. Now I can just take the absolute value of 31, that's 31. But really, I don't even need to do that at this point. If I see the absolute value of just a number, and I know what negatives are outside, I can just use my shortcut. I know the answer would just be negative 31. So once you get comfortable with that, you can go ahead and stop at this point and write your answer. But again, the slow way, replace this with 31. So we'd have the opposite of, the opposite of, the opposite of 31. So now we would change the sign here. So the opposite of 31 would be negative 31. So we'd have the opposite of negative 31. Change the sign again. The opposite of negative 31 would be positive 31. So we'd have the opposite of positive 31. Change the sign one more time. The opposite of 31 is negative 31. And that will be our answer. But again, once you get to this step and you know what number is going to be inside the absolute value operation, you can use your shortcut. Absolute value just makes the number 0 or positive. So you can just think about that number that's going to result and then think about the negatives that are outside of that absolute value operation and get your answer. In this case, we knew the answer would be 31, and then we think about 1, 2, 3 of those guys. 3 is an odd number, so we would have a negative applied to it. So you'd have negative 31. Hello and welcome to Pre-Algebra Test Section 1 on absolute value. Okay, for the problems, we just want to find the absolute value for each. And finding the absolute value is very, very simple. If we have a negative number, we just make it positive. If we have a positive number or 0, we just keep it the same. So for the absolute value of negative 2,395, we just make it positive, right? Because it's a negative. So positive 2,395. That's all we need to do. We are done. What about the absolute value of negative 1? Well, again, if it's negative, just make it positive. So this would just be 1. What about the absolute value of 975? Well, this is a positive number, so it just stays the same. So it would just be 975. What about the absolute value of 641? Well, again, it's a positive number, so it just stays the same. So 641. What about the absolute value of negative 11? Well, again, if it's negative, you just make it positive. So the absolute value of negative 11 is 11. What about the absolute value of negative 18? The absolute value of negative 18 is just 18, right? If it's a negative value, just make it positive. And for the last one, what about the absolute value of 0? Again, if it's 0 or any positive number, just keep it the same. So the absolute value of 0 is 0. Hello and welcome to Pre-Algebra Test Section 2 on absolute value. Okay, now we want to just replace the question mark with less than, greater than, or equal to. So we're going to begin with the absolute value of negative 3, question mark, the absolute value of 25. So just think about this before you put the symbol in there. If I think about the absolute value of negative 3, it's just 3. Right? If you have a negative number, and you take the absolute value of it, you just make it positive. For the absolute value of 25, it's a positive number. So when you take the absolute value of a positive number, you just keep it the same. So this would be 25. So thinking about the relationship between 3 and 25, 3 is the smaller number. So I would use a less than here because the absolute value of -3 would be 3, and that is less than the absolute value of 25, which is 25. Again, the symbol always points to the smaller number. What about the absolute value of -7? Question mark the absolute value of 15. Well, again, thinking about this, if we take the absolute value of a -7, it's just going to be +7. Right? Just make it positive. The absolute value of 15 will just be 15. Right? If it's a positive number, just keep it the same. And so we know 7 is the smaller number. So we're going to use a less than here. The absolute value of -7, which is 7, is less than the absolute value of 15, which is 15. Again, you point the symbol to the smaller number. What about the absolute value of 31? Question mark the absolute value of -31. The absolute value of 31 and the absolute value of -31. Remember, these two numbers are what we call opposites. So they have the same distance from 0 on the number line, but they lie on opposite sides of the number line. We learned in our lesson that opposites have the exact same absolute value. So in each case, the result would be the same, right? The absolute value of 31 is 31. The absolute value of -31 is also 31. So these two are equal, right? Because when you do the absolute value operation, it ends up being 31 equals 31, right? The same number on each side. Here we have the absolute value of 752, question mark, the absolute value of -5,015. Okay, so again, thinking about these numbers, we know that the absolute value of 752, it's a positive number, is just 752. The absolute value of -5,015, if it's a negative, just make it positive, so it would be 5,015. Very, very easy to do. Clearly, this is the smaller number, so we would use a less than here, right? The absolute value of 752, which is 752, is less than the absolute value of -5,015, which is 5,015. Right? Again, use the symbol that points to the smaller value, and in this case, that's the absolute value of 752. Again, point the symbol towards the smaller number. So for the next one, we have the absolute value of 0, question mark, -25. So the absolute value of 0 and -25. Now notice how -25 is not inside of absolute value bars. We are not performing that operation here. So the absolute value of 0 is just 0. So if I think about 0 and -25, I know that 0 is a bigger number, right? I would use a greater than there. And again, the reasoning for this, if you owe nothing or have nothing, you're better off than if you owe $25 to somebody, right? If you have nothing, no debts, but you don't have anything, you're better off than if you owe somebody $25. So we're going to use a greater than here. The absolute value of 0 is greater than -25. Hello and welcome to Pre-Algebra Test Section 3 on absolute value. Okay, for the first problem, we have the absolute value of 75 plus 2 squared, then we have our question mark, and then we have the absolute value of -79. So if we think about what the value will be after we apply the absolute value to the 75 plus 2 squared, well, we have multiple operations involved inside the absolute value bars. We have 2 squared and we have an addition. Now, exponents take the highest priority, so we would figure out what 2 squared is first. 2 squared is 4, so we would essentially have the absolute value of 75 plus 4. Now, 75 plus 4 is 79, and so we would have the absolute value of 79 there. Now, the absolute value of 79 is just 79. Now, looking over here, we have the absolute value of -79, and we know that's also 79, right? If you have a negative value and you take the absolute value of it, it just becomes positive. So these two are equal, right? Because they result in the same number, 79. So the absolute value of 75 plus 2 squared is going to be equal to the absolute value of -79. Right? Those two will, again, result in the number 79 once you've done everything. All right, for the next one, we have the absolute value of, and then we have 3 squared times 5 minus 7, then our question mark, and then the absolute value of -115. So I'll start over here because this one's really easy. The absolute value of -115 is just 115. And just think about the operations involved inside of the absolute value bars there. So we'd have 3 squared times 5 minus 7. You have an exponent, you have multiplication, and you have subtraction. The exponent is the highest priority. So 3 squared is 9, right? It's 3 times 3. So this would be 9, and then times 5 minus 7. Your next highest priority is multiplication. So you do 9 times 5 next. And 9 times 5 is 45, and then minus 7. And now you're just left with subtraction. 45 minus 7 is 38. So the result of this is going to be 38. Let's just write that there. Now, when you take the absolute value, of 38, you'd still get 38, right? Because the absolute value of a positive number is just itself. So thinking about 38 and 115, I know that 38 is the smaller number. So we're going to use a less than symbol here. So we would have the absolute value of 3 squared times 5 minus 7 is less than the absolute value of negative 115. And this is because, again, once we go through and perform all the operations involved, you'd end up with 38 is less than 115. Okay, for the next one, we have the absolute value of 10 squared divided by 4 plus 8. Then we have our question mark. And then we have the absolute value of 32. So again, this one's easy. The absolute value of 32 is just 32. And thinking about the operations in here, let's just figure out what's the result of what's inside the absolute value bars. So we have 10 squared divided by 4 plus 8. You have an exponent, you have division, and you have addition. So the exponent is the highest priority. So 10 squared is 10 times 10, that's 100. Then divided by 4 plus 8. Now, division is the next highest priority, right? You have division and addition. So 100 divided by 4 is 25. So we would say this is 25, then plus 8. And then our final operation would give me 33, right? 25 plus 8 is 33. So this would be 33. If we take the absolute value of 33, we get 33. So we're basically comparing 33 and 32, and we know 33 is bigger. So we would say that the absolute value of 10 squared divided by 4 plus 8 is greater than the absolute value of 32. And again, the result of this, once you've done everything, is 33. The result of this, once you've done everything, is 32. So 33 is greater than 32. That's why our symbol is pointing to the right, right? We have it pointing towards the smaller value. Okay, let's take a look at one final problem. So we have the absolute value of, and then inside of parentheses, we have 5 cubed divided by 5, then plus 11, question mark, and then we have the absolute value of 2 times this quantity 6 minus 4, then plus 9 squared. So we have to think about what's involved inside the absolute value bars in each case, and then come back, take the absolute value, and figure out, the relationship between the two. So let's just write this, forget about the absolute value bars for now. 5 cubed divided by 5 inside of parentheses plus 11. So in any problem, you always start out inside of parentheses. Once we're in there, we reapply the order of operations. We have division and we have an exponent. So we do the exponent first. So what is 5 cubed? What is 5 times 5? That's 25. Then times 5 again, that's 125. So we would have 125 divided by 5 plus 11. So this is inside of parentheses. This part is not. Now, we look inside the parentheses because, again, that's the highest priority in any problem. We just have the division. So 125 divided by 5 is going to put us back to 25. So now we'll have 25 plus 11. And then if we add these two, let's just do that vertically. So 25 plus 11. 5 plus 1 is 6. 2 plus 1 is 3. So that's 36. So after everything is said and done, the result of this right here, would be 36. Now, when we take the absolute value of 36, we get 36, right? Take the absolute value of a positive, you just get that number back. Now, working over here, we'll do the same thing. Forget about the absolute value bars. We'll have 2 times the quantity 6 minus 4, then plus 9 squared. Work inside the parentheses first. So you'd have 6 minus 4, and that's going to give you 2. So we would have 2 times 2, then plus 9 squared. And again, remember, when you have a number next to a set of parentheses, it implies multiplication. If you're more comfortable, we can write this like this, 2 times 2. Now, looking at the operations we have left, we have an exponent, we have addition, and we have multiplication. We need to do this exponent first. It's our highest priority. So 9 squared is 9 times 9, that's 81. So we'd have 2 times 2 plus 81. Now we have multiplication and addition. We want to multiply before we add. 2 times 2 is 4. So we'd have 4 plus 81. And if we do that, 4 plus 81 is 85. Okay, so the result of this right here is going to give us 85. So when we take the absolute value of 85, again, because it's a positive number, it stays positive. It's just going to be 85. So thinking about 36 and 85, 36 is smaller, right? 36 is going to be less than 85. So we're going to use a less than symbol here. Let me just rewrite this. We would have the absolute value of 5 cubed divided by 5, that's inside of parentheses here, plus 11 is going to be less than, remember, because the result of this was 36, the absolute value of 2, and then this is multiplied by this quantity, 6 minus 4, plus, and then we have 9 squared. Remember, this result was 85. So this is going to be less than this, because at the end of the day, once we've done all the operations involved, this result is going to be 36, and this result is going to be 85. So 36 is less than 85, so that's where we're using a less than here. Hello, and welcome to Pre-Algebra Test Section 4 on absolute value. Okay, for the problems we're going to look at, we just want to simplify. Okay, for the first problem we're going to look at, we have the opposite of the absolute value of negative 173. So some of you might immediately say, okay, I have 1, 2 of these symbols. 2 is an even number, so I know my answer is positive 173. That would be wrong here, and let me explain why. So if you recall, we did a lesson where we talked about integers and opposites. And we did some simplification there. So something like the opposite of negative 173. I could count the number of negatives I have. If it's an even number, the result is positive. So in this case, I have 2, that's even. I get 173. If I had another negative involved, then I would have 3 negatives. 3 is an odd number. The answer would be negative, all right? Each pair of negatives basically just makes a positive. So the opposite of negative 173, this would become positive, and then it would become negative. So we know that at this point. But if you try to apply that here, it's not going to work. And the reason is because you have to treat whatever you see here as a positive. Once you apply the absolute value operation, remember the result is never going to be negative. So you can't count the negative sign inside of the absolute value operation, because once you perform the absolute value operation, it's not going to exist. So just to see this, the absolute value of negative 173 is 173. So it would just have the opposite of 173, and that is negative 173, right? So if you have a problem like this, you just count the negatives outside of any absolute value bars that you have. You can't count the ones that are inside. Again, that's because I'm just looking at this problem here, the opposite of 173. Right? Once I apply the absolute value, it's going to make the number positive. So that's why we end up with this negative 173. Okay, now we have the opposite of, the opposite of, the opposite of, the opposite of, and then we have the absolute value of 3 to the 4th power minus 8. Okay, so what we would do here, we would perform the operations inside of the absolute value bars first. Once we get this down to a single number, where we're saying, okay, we're taking the absolute value of some number here, we could use our trick. We would just count the number of negatives we have outside the absolute value bars. In this case, we have 1, 2, 3, 4. 4 is an even number. So at the end of the day, the result is going to be positive, right? So let's just work on this part first. 3 to the 4th power minus 8. So I would perform this operation first, right? I would figure out what 3 to the 4th power is. And when I'm done with that, then I'm going to subtract away 8. So 3 to the 4th power is 3 times 3, that's 9, times 3 again, which is 27, times 3 one more time, which is 81. So we'd have 81 minus 8. So 81 minus 8 is 73. So I could replace this. Let me just rewrite all of this real quick. I can replace this with a 73. So the opposite of, the opposite of, the opposite of, the opposite of, and then the absolute value of 73. So once I get my problem to this point, I can stop because I can get the answer. I can look at this now and say, okay, I know the answer is positive 73. How did I know that? I have a single number inside the absolute value operation. I know that this makes it positive. And then I have 1, 2, 3, 4 negatives involved. 4 is an even number, so I'm going to have a positive result. So I could stop at this point and just say, okay, the answer is 73. Or I could go through it the long way. I could go through it the long way and say, okay, we're going to have the opposite of, the opposite of, the opposite of, the opposite of, and then this will be 73, right? The absolute value of 73 is just 73. Now we would go through and say, okay, this would make it negative, then positive, then negative, then positive. So again, we'd end up with just 73 as our answer. Okay, so let's think about this one. We have the opposite of, the opposite of, the opposite of, and then we have the absolute value of negative 212. All right, so if we think about this, again, it's a perfect place to use your trick. We know that the result of what's inside here is going to be positive, right? It's going to be positive. And in this case, it's going to be a positive 212. But even just ignoring that for a second, I would count the number of negatives that I have outside the absolute value operation. I see that I have 3. 3 is an odd number, so I'm going to end up with a negative result here. All I have to do is figure out what the result of the absolute value of negative 212 is, then just slap a negative on there, and I'm done. So the absolute value of negative 212 is 212, and so we end up with negative 212 as our answer. Again, if you want to go about this the slow way, take the absolute value first. So we'd have the opposite of, the opposite of, the opposite of. The result of this, the absolute value of negative 212 is 212. Now, starting here and just working your way outward, this would become negative, then positive, and then negative. So again, you'd end up with negative 212. Hello and welcome to Pre-Algebra Test Section 5 on absolute value. Okay, so we want to simplify. So we're looking at the opposite of, and then inside of parentheses here, we have the opposite of, the absolute value of 2 squared divided by 4, then plus the absolute value of 5 plus 7. So kind of to start this problem, I would think about it using the order of operations. So I have this negative here, and then inside of the parentheses I have another negative, and then inside the absolute value bars I have 2 squared divided by 4. Now I want to apply that exponent before I divide. Exponents are a higher priority. So 2 squared is 2 times 2, that's 4. So I would write this as 4 divided by 4. And then plus, I'm just going to copy the rest of the problem, the absolute value of 5 plus 7. Now continuing, now I would do 4 divided by 4. 4 divided by 4 is just 1. So I'm going to replace this part right here with a 1. So the opposite of, and we have the absolute value of 1, and plus the absolute value of 5 plus 7. So then continuing, now the absolute value of 1 is just 1. So I'd have the opposite of, the number 1. Okay, plus. Now we have the absolute value of 5 plus 7. We could just go ahead and do that. 5 plus 7 is 12. So we'd have the absolute value of 12. So now we have the opposite of, the number 1, and plus the absolute value of 12 would just be 12. Okay, so the opposite of 1 is negative 1. So I would have the opposite of negative 1 and then plus 12. So now the opposite of negative 1 is 1. So we'd have 1 plus 12, and this is just 13. All right, let's look at one more. We have the opposite of, the opposite of, the opposite of, the opposite of, the absolute value of 6 squared divided by 9 plus 7. Okay, so let me just recopy this. The opposite of, the opposite of, the opposite of, the opposite of, and then the absolute value of. So inside of here, the highest priority is this exponent. So we'd have 6 squared, that's 6 times 6, that's 36. So I'm going to write 36 divided by 9 plus 7. Okay, continuing. If I look inside the absolute value bars now, my highest priority is that division. 36 divided by 9 is 4. So I'm going to have the opposite of, the opposite of, the opposite of, the opposite of, and then the absolute value of. This will be 4, then plus 7. And just to kind of make this shorter, I can just replace 4 plus 7 with 11. I don't need to do an extra step for that. So let's just make this 11. Okay. Now at this point, I have my answer. Okay, and you might be saying, what are you talking about? Well, look at what I have here. I have 1, 2, 3, 4 negatives that are outside of an absolute value operation that just contains a number. We know that when we take the absolute value of a positive number, it's just the number. So at this point, it's the same as if I just had the opposite of, the opposite of, the opposite of, the opposite of 11. And we know using our shortcut that that would just be 11, right? We don't need to go any further. But if you want to go about it the slow way, you can say, okay, well, this is going to be 11. So the opposite of, the opposite of, the opposite of, the opposite of. I'm going to put 11 inside of parentheses. And then we're going to work our way outward. So this would be negative, then positive, then negative, then positive. So again, we end up with positive 11. Hello and welcome to Pre-Algebra Practice Set number 19. And in this video, we're going to look at some additional practice problems for our lesson on adding integers. Okay, so we want to add using a number line, and we'll start out with 1 plus 6. So we all know how to do 1 plus 6. We start out at the leftmost number, which is 1, and then we're adding 6. So if we're adding a positive number, we're just moving to the right by that number of units. So what I'm going to do is I'm going to go to the right. I'm going to go 1, 2, 3, 4, 5, 6 units to the right, and we end up at 7. Right? So 1 plus 6 equals 7, and of course we all know that. Okay, what if we had negative 2 plus negative 7? So we start out at the leftmost number, negative 2. So we're going to start out right here on our number line. Now I'm adding negative 7. So when I add a negative, I'm moving to the left. Just think about subtracting 7 units away. You'd move to the left 7 units. That's exactly what we're doing here. If we're adding a negative 7, it's the same thing as taking 7 away. I'm going to go to the left 7 units. 1, 2, 3, 4, 5, 6, and then 7. So I end up at negative 9. So negative 2 plus negative 7 equals negative 9. Okay, what if we had negative 1 plus negative 5? Again, we start out at the leftmost number, so we start out at negative 1. We're adding a negative 5. Okay, so we're just moving to the left by 5 units. Just think about adding a negative 5 as just subtracting 5 away. Okay, I'm taking 5 more away. So I'm going to go 5 units to the left. 1, 2, 3, 4, 5. Okay, I end up at negative 6. So negative 1 plus negative 5 is negative 6. And again, think about this using money. Let's say you owe $1 to your father and you owe $5 to your uncle. If you said, well, what's my total debt between these two people? Well, you could represent that with a negative 6. You could say, hey, I owe $6. Let's say I have 9 plus negative 8. So I start out at 9 on the number line. That's right here. And I'm adding a negative 8. So that means I'm moving to the left 8 units. Okay, again, if I'm adding a negative, I'm going to the left. So in this case, it's a negative 8. So I'm going to the left 8 units. So 1, 2, 3, 4, 5, 6, 7, and then finally 8 to end up at 1. So 9 plus negative 8 equals 1. And again, you could just think about this. Let's say I had $9 in my wallet. And let's say I owe my brother $8. Well, what do I have total? Well, I take the $9 that I have and I add it to the debt that I have of $8. Well, if I took the 9 and I paid off the debt of $8, I'd only have 1 left. Okay, let's look at one with more than 2 integers. So we have 7 plus negative 6 plus 4 plus negative 2. So we just start out at the leftmost number. So we're going to start out at 7. And then I'm adding negative 6. So I'm just going to the left 6 units. So let's change our pen. So we're going to go 1, 2, 3, 4, 5, and then 6. So that's going to put me at 1. Now I'm going to add 4. So I'm going to add 4. So I'm going to go 1, 2, 3, 4 units to the right. Okay, so that's going to put me at 5. Now finally, I'm going to add a negative 2. So if I'm adding a negative 2, I'm just moving to the left 2 units. So let me change colors to purple. And I'm starting here, and I'm going to go 1, 2 units to the left to end up at 3. So this equals 3. Okay, so now we have add without a number line. We start out with negative 3 plus negative 8. So when we add integers and they have the same sign, it's very, very simple. All you do is add the absolute values of the numbers, and you just attach the common sign. So I'm just going to pretend both of these numbers are positive. So I would think about 3 plus 8. What is 3 plus 8? That's 11. Then I just use the common sign. The common sign is negative, so I just slap that on. So negative 3 plus negative 8 is negative 11. And if you ever get lost, just think about your bank account. You have a balance of negative $3. You go out and you spend 8 more. What's your balance now? Well, you know you're going to have negative $11 because you had a debt of 3 and you spent 8 more. 3 plus 8 is 11, and we're talking about things that are debts, so we have a negative value. What about negative 7 plus negative 2? Again, the same thing. We're adding 2 negatives, so the result will be negative. And then I just think about the absolute values of the numbers. 7 plus 2 is 9. So negative 7 plus negative 2 is just negative 9. All right, now let's look at some where we have mixed signs involved. And this is just a little bit more tedious, but it's not very hard. So 14 plus negative 23. Okay, so the first thing I want to do is think about the absolute value of each number. So the absolute value of 14 is 14. The absolute value of negative 23 is 23. Now, I want to use the sign of the number that has the larger absolute value. In this case, that is going to be negative 23. So we're using its sign. So the result will be negative. Now, what we want to do is we want to subtract the larger number minus the smaller number. So we would do 23 minus 14. So I would borrow here. 13 minus 4 is 9. So I would end up with a negative 9 as my answer. And again, you can use money for this. If I have $14 in my bank account and I go out and I spend 23, well, I spent $9 more than I had. So what happens is I now have a bank balance that says negative $9. What about negative 5 plus 8? Well, again, what's the absolute value of each number? So the absolute value of negative 5 is 5. The absolute value of 8 is 8. So 8 has the larger absolute value. So we use its sign. Its sign is positive. So you can either put a plus out there to remind yourself the answer is positive, or you can just leave it blank, whatever makes you feel more comfortable. So now I just want to subtract. And you could say, okay, I'm going to subtract the larger number minus the smaller number, or you can say, hey, I'm taking away the smaller number from the larger, whatever you want to say. So we're basically going to do 8 minus 5, 8 minus 5, and we know that's 3, right? We know that's 3. And again, thinking about this using money, I want to just drill this into your head so if you get stuck on a test, you can kind of visualize what's going on. I owe $5 to my dad. I get $8 in from, let's say, mowing a lawn. Well, now, if I think about those two things, I have $8 and I have a debt of 5. I could take the 8, I could pay off my debt of 5, and I'd still have $3 left over. So negative 5 plus 8 is going to give me a positive 3. All right, let's look at adding more than 2 integers. And again, the easy way to do this is just add the numbers with a common sign, and then you'll do your mixed addition last. So we have 3 plus negative 6 plus 1 plus negative 4. Let's reorder this. 3 plus 1 plus negative 6 plus negative 4. I just like to write my numbers with common signs next to each other. It makes it easier for me to do the addition mentally. So 3 plus 1 is 4, plus negative 6 plus negative 4. Again, use your common sign in the answer, so it's negative. And then just add the absolute value. So 6 plus 4 is 10. So we get negative 10 there. And now we're just adding. We have 4 plus negative 10. So kind of thinking about this, I have $4 in my wallet and I spend 10. I'm going to owe $6, right? Because I spent $6 more than I had. But again, kind of thinking about this the traditional way, take the absolute value of each number. The absolute value of 4 is 4. The absolute value of negative 10 is 10. And we know that the absolute value of negative 10 is larger, right? It's 10. So we use its sign in the answer. So its sign is negative, and then we would subtract. We would take the smaller number away from the larger when we think about the numbers in absolute value. So we would do 10 minus 4, and that gives me 6, right? So bring that up here. And of course, we end up with negative 6 as our answer. All right, now we have negative 30 plus 18 plus negative 24. So let's add negative 30 and negative 24 first. So to do that, the sign is going to be negative, right? That's the common sign. And we think about just 30 plus 24, right? Thinking about the numbers in terms of their absolute values. So 0 plus 4 is 4, 3 plus 2 is 5. So this would be negative 54. And now I want to add 18 to that. Okay, so again, think about these numbers in terms of their absolute value. So this would be 54, this would be 18. Now, 54 is the larger number, so we would use the sign from negative 54 in our answer. So it's going to be negative. Now I want to subtract 54 minus 18. So 54 minus 18, 14 minus 8 is 6, 4 minus 1 is 3. So this is going to give me 36 here. And when I bring it up here and I attach the negative to it, I end up with a negative 36 as a result. All right, what if we have negative 20 plus 15 plus negative 32? So again, I'm going to add these two negatives first. And that's kind of easy to do in my head. So I have negative 20 and negative 32. I know that's negative. 20 plus 32 is 52. And I kind of just mentally did a vertical addition. But just for the sake of completeness, let's go ahead and do that. 0 plus 2 is 2. 2 plus 3 is 5. So this is negative 52. Okay, now we're adding to that 15. And again, think about these numbers in terms of their absolute values. So negative 52, the absolute value of that is 52. And the absolute value of 15 is 15. So the first thing is we know the sign is going to be negative, right? Because the absolute value of negative 52 is greater than the absolute value of 15. And then we're going to subtract 15 away from 52. So we're basically going to do this problem here. So 52 minus 15. And let me just kind of scroll over a little bit. So this would be 4. 12 minus 5 is 7. 4 minus 1 is 3. So you get 37 there. So this equals 37. So the answer is going to be negative 37. Okay, let's look at one final problem. We have 17 plus negative 28 plus negative 34 plus 42. So again, I'm going to think about adding the positive numbers together first, then the negative numbers together, and then we'll do a mixed addition. So what is 17 plus 42? So let's write this as 17 plus 42 plus negative 28 plus negative 34. And again, what is 17 plus 42? 42 plus 17. 2 plus 7 is 9. 4 plus 1 is 5. So we're going to write this as 59. 59 plus negative 28 plus negative 34. Next, let's think about this. What is negative 28 plus negative 34? Well, again, if we're adding two numbers with the same sign, we use that common sign in the answer. So we'd have a negative, and then we just add the absolute value. So 28 plus 34. So 28 plus 34. 8 plus 4 is 12. 1 plus 2 is 3. 3 plus 3 is 6. So that is 62. Slap that negative on it. You get negative 62. All right, so now we're left with 59 plus negative 62. And again, I have a balance of $59 in my checking account, and I spend 62. Well, we all know we're now going to have a balance of negative $3 in our checking account. Right? You should be able to do that without going through the operation because I spent $3 more than I had. But again, to kind of do this, the absolute value of 59 is 59. The absolute value of negative 62 is 62. And so, again, I use the sign of the number with the larger absolute value. So the sign of this answer is going to be negative. And then we're subtracting absolute values. So we're doing 62, the larger number, minus 59, the smaller. So this will be 5. 12 minus 9 is 3. And 5 minus 5 is 0. So again, drag this up here. And again, you get negative 3. Hello and welcome to Pre-Algebra Test Section 1 on adding integers. Okay, we want to add each using a number line. And we're going to start out with negative 5 plus negative 7. So what we're going to do here is we're going to start out at the leftmost number of the addition problem on the number line. So here's negative 5. Let me highlight that guy. So that's negative 5. Now I'm adding negative 7. So what I'm doing is, if I'm adding a negative 7, that's just telling me that I'm moving to the left 7 units. So I'm going to go 1, 2, 3, 4, 5, 6, and then 7. So I end up right here, and that's going to put me at negative 12. So negative 5 plus negative 7 is negative 12. Okay, what about negative 6 plus negative 8? Again, I'm going to start out at the leftmost number. So I'm going to start out here at negative 6. And then I'm adding a negative 8. So I'm going to move to the left 8 units. And let me just highlight this real quick. I'm going to move to the left 8 units. So 1, 2, 3, 4, 5, 6, 7, and then finally 8. So we end up right here. And that's going to put us at negative 14. Okay, negative 14. Okay, now let's add negative 2 and 4. So to add negative 2 and 4, we basically start out at the leftmost number. Again, we're going to start out at negative 2. So that's right here. And I'll go ahead and highlight that. And then if I add 4, I'm just moving to the right 4 units. When you're adding a positive, you're moving to the right by that number of units. If you're adding a negative, you're moving to the left, you could say, by the absolute value of that number's units. So basically, if I was adding negative 4, I would just go to the left 4 units. Or if I was adding negative 12, I'd go to the left 12 units. I'm adding 4 here, so I'm moving to the right 4 units. So 1, 2, 3, finally 4, and I end up at 2. Okay, so I end up at 2. So negative 2 plus 4 is 2. Hello and welcome to Pre-Algebra Test Section 2 on adding integers. All right, so we want to add each using a number line, and we're going to start out with negative 7 plus 14 plus negative 11 plus 4. So when we add a positive number, so let's say I'm adding 3, I'm moving to the right by that number of units, so I'd move to the right 3 units. If I add a negative number, I'm going to move to the left by the absolute value of that number's units. So if I'm adding, let's say, negative 6, the absolute value of negative 6 is 6, so I'd move to the left 6 units. So if I look at this, I start out at the leftmost number. So I start out at negative 7. So that guy's going to be right here. And let's just highlight that to be clear. And then I'm adding 14. So that means I'm moving 14 units to the right. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and then 14. So that puts me here at 7. Okay, that puts me at 7. Let me just highlight that guy. So now I want to add a negative 11. So that means I'm going to move to the left 11 units. I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then lastly 11. So that puts me at negative 4. So right here. The last thing I'm going to do is I'm going to add 4. So that's a movement to the right 4 units. So let's do that in purple. So starting here, I'm going to go 1, 2, 3, and then 4. And so I end up at 0. Okay, that's where I end up. So here's my answer for the problem. So negative 7 plus 14 plus negative 11 plus 4 gives me 0. And you can kind of look at this and mentally see why. If I add negative 7 and negative 11, again, adding negatives, you keep the sign the same, so it would be negative, and then you just do the absolute values. So 7 plus 11 is 18. So I'd have negative 18. And plus, if I think about 14 plus 4, that's also 18. If you add a number and its opposite, you always get 0. So negative 18 plus 18 is 0. So that's why we ended up at 0 here. Okay, for the next problem, we have negative 5 plus 2 plus negative 6 plus 1 plus negative 3. So we're going to start out at negative 5 on the number line. So that's right here. Let's highlight that guy. And we're going to add 2. So that means we're just going to move 2 units to the right. So I'm just going to go 1, 2 units to the right. That puts me at -3. Now I'm going to add -6. So that means I'm moving 6 units to the left. So let's do that in a purple. So I'm going to go 1, 2, 3, 4, 5, and then 6 units to the left. Let's highlight that guy. So now I'm at -9. And I want to add 1. So that means I'm just going to move 1 unit to the right. So we'll do that in kind of a dark blue. So 1 unit to the right. And that's going to put me at -8. So let's highlight that. And then we have one more movement to do. We're adding a -3. So if we're adding a -3, that means we're moving 3 units to the left. So we can do that in a maroon. So we'll start right here. We're going 1, 2, 3 units to the left. And we end up at -11. And let me kind of highlight our answer with kind of a different color. So -11 is our result. -11. And again, just kind of add this without the number line. If I look at the numbers that are the same, meaning they have the same sign, -5 plus -6 would be -11. Right? You keep the common sign, which is negative, then you just do 5 plus 6, that's 11. So you combine the negative and the 11, you get -11. Then you add a -3 to that. So you get -14. Right? If you had -11 plus a -3, the sign would be negative, and you just do 11 plus 3, that's 14. Okay, so now having -14, I'm thinking about our positive values here. I have 2 plus 1, that's 3. So I'm adding 3. So what is -14 plus 3? Well, again, use the sign of the number with the larger absolute value. So we're using the sign from -14. And then we want to subtract absolute values, but we want to subtract the smaller absolute value from the larger. So we would do 14 minus 3, and that's 11. So we end up with -11. Again, exactly what we got here using the number line. Hello and welcome to Pre-Algebra Test Section 3 on adding integers. All right, so we want to just find each sum, and we're going to start out with -15 plus -30. All right, so when we add integers and they have a common sign, we just keep the common sign. So in this case, we're adding 2 negatives. So the common sign is negative, so we're just going to keep that sign. And then you just add the absolute values of the numbers. So you think about this just as 15 plus 30. Most of you know that's 45, but just for the sake of being complete, let's do a vertical addition. 0 plus 5 is 5. 3 plus 1 is 4. So we have 45 there. And you just stick it up there next to the negative, and we have -45 as our answer. What about -2 plus -8 plus -17? Well, in this problem, everything is a negative. So the answer is going to be negative. And then we can just add absolute values. So you think about 2 plus 8 plus 17. Well, 2 plus 8, you can do that in your head. That's 10. And then 10 plus 17. 10 plus 17. Well, let's do this in vertical addition format. 7 plus 0 is 7. 1 plus 1 is 2. So we get 27. All right, so I'm going to write that next to that negative. And so our answer here is going to be -27. Okay, then what about -4 plus -7 plus -1? Well, again, everything here is a negative, so my answer is negative. And then I can just add absolute values. 4 plus 7 would be 11, and then add one more, that would be 12. Stick that next to that negative, and you end up with -12. Okay, for the final problem, we have -12 plus -22 plus -13 plus -40. So we know that the result here is going to be negative, right? We have all negative numbers involved. I just need to go through and add absolute values. So let's do a vertical addition with 12, 22, 13, and 40. And again, all I did was just take the absolute value of each number. All right, so 2 plus 2 is 4, 4 plus 3 is 7, 7 plus 0 is still 7. 1 plus 2 is 3, 3 plus 1 is 4, 4 plus 4 is 8. So you'd end up with 87 there. Again, you're going to stick that next to the negative because we already figured out this answer would be negative. And we're done. Our answer here is -87. Hello and welcome to Pre-Algebra Test Section 4 on adding integers. All right, we just want to find each sum. Okay, so we're going to start out with 6 plus -7. So in the lesson I taught you, basically there's 2 steps to this. The first step is just figuring out what the sign is, or you can kind of think about these steps. You can switch what's first and what's second. It doesn't really matter. But the first step is figure out what the sign is. And the way you do that is you think about which number has the larger absolute value. So if I look at 6, the absolute value is 6. If I look at negative 7, the absolute value is 7. Negative 7 has a larger absolute value, and so we will use its sign in the answer. So we will put a negative there, and then we'll figure out the number part. We know the sign is negative. What's the number part? Well, to do that, you subtract absolute values. So you think about, we already have the absolute values there. You'd subtract the smaller from the larger. So you would just do 7 minus 6, and that would give you 1. Okay, that would give you 1. So the answer here is negative 1. And logically, if you think about this, let's say you have $6 in your bank account and you spend 7. You're going to end up with a balance of negative $1, right? Because you spent $1 more than you had. What about negative 4 plus 3? Again, think about the sign of the answer. So the absolute value of negative 4 is 4. The absolute value of 3 is 3. The absolute value of negative 4 is larger, so we're going to use its sign in the answer, right? So the answer will be negative. And now you just subtract absolute values. You're just going to do 4 minus 3, right? 4 minus 3 is 1. So the answer here is negative 1. What about 12 plus negative 1? Again, what's the absolute value of each number? So this one would be 12. This one would be 1. So 12 has a larger absolute value, so the sign for the answer will be positive. So you can put a positive out here to remind yourself you already did it, or you can just leave it blank. It doesn't really matter. We'll just leave that out there. And then we're going to subtract absolute values. So we'll do 12 minus 1, and that gives us 11. Right? 12 minus 1 equals 11. So our answer here is going to be positive 11. And again, just think about this as, okay, I have $12 in my wallet, and I take 1 away. Now I'm going to have 11. Or I have $12 in my wallet, and I owe somebody $1 somewhere. Right? It's the same thing, because you have to take that dollar away from me to pay that debt off. So really, if I add those two amounts together, the amount I have plus my debt, this is going to be my total, right? I'm really worth $11 right now. I have 12 on me. I got a debt of 1. My total amount that I'm worth is $11. What about 15 plus negative 9? Again, what's the absolute value for each? So the absolute value of 15 is 15. The absolute value of negative 9 is 9. So we're going to use the sign of the number with a larger absolute value, and that's 15. Right? So this guy's going to be positive. Then we're going to subtract. We're going to do 15 minus 9. 15 minus 9 is 6. So we'll end up with positive 6 as our answer. Again, not to beat a dead horse, but you have $15 in your wallet, and you owe somebody $9. If you were to take $9 out and pay that debt off, you would only have 6. Right? That's what this is saying. 15 plus a negative 9 is 6. What about 34 plus negative 28? Well, what's the absolute value of 34? That's 34. The absolute value of negative 28 is 28. And so this answer is going to be positive because 34 has a larger absolute value. And then we just subtract. What is 34 minus 28? We'll borrow here. 14 minus 8 is 6. So we end up with positive 6 as our answer. Hello and welcome to Pre-Algebra Test Section 5 on adding integers. All right, so we just want to find each sum. We're going to start out with negative 25 plus 17 plus negative 27 plus 60. So when you run across problems like this, you want to reorder everything and put your negatives next to each other and put your positives next to each other. You don't have to do that, but typically it's going to help you because in a problem like this, most people are going to add their negatives together and their positives together separately, and then they'll do kind of the mixed addition last. So if I add negative 25 and negative 27, it's easy to do. I know the sign is negative, and then I just add the absolute values. So I'll do 25 plus 27. 5 plus 7 is 12. 1 plus 2 is 3, plus 2 is 5. So I'll end up with a negative 52. Now if I want to add 17 plus 60, so 17 plus 60, 7 plus 0 is 7, 1 plus 6 is 7, I'd get 77. So now we have an addition where we have different signs. Remember, we use the sign of the number that has the larger absolute value. So the absolute value of negative 52 is 52. The absolute value of 77 is 77. So the absolute value of 77 is larger, right, than the absolute value of negative 52. So the sign of the answer will be positive. And now we just want to subtract, right? We would do 77, which is the larger absolute value, minus 52, which is the smaller absolute value. 7 minus 2 is 5. 7 minus 5 is 2. So you'd end up with positive 25 as your answer. Okay, let's look at another one. We have negative 40 plus 15 plus negative 22 plus negative 18 plus 55. All right, so again, I'm just going to reorder everything to where all the negatives are next to each other and all the positives are next to each other. And again, as you move forward, you're probably not going to do that. You can just kind of add this stuff in your head. But just for the sake of completeness, let's reorder everything. So negative 40 plus negative 22 plus negative 18, then plus 15, then plus 55. Okay, so let's add all our negatives together first. So I know the result will be negative, and then I can just add absolute values. So I can think about 40, 22, and 18. And what's the sum here? 0 plus 2 is 2. 2 plus 8 is 10. 1 plus 4 is 5. 5 plus 2 is 7. 7 plus 1 is 8. So I'd end up with negative 80. And now I just want to add the positive numbers. 15 plus 55. Okay, a lot of you at this point know that's 70. But for the sake of completeness, again, let's do it using a vertical addition. 5 plus 5 is 10. 1 plus 5 is 6. 6 plus 1 is 7. So again, this is 70. And now we have one final step to do. We have a negative and a positive. When this happens, again, we use the sign of the number that has the larger absolute value. So the absolute value of negative 80 is 80. The absolute value of 70 is 70. So negative 80 has a larger absolute value, so we're going to use its sign in the answer, right? So the answer is negative. Now we just subtract absolute values. We take the larger absolute value, which is 80. We subtract away the smaller, which is 70. 80 minus 70 is 10. So you slap that up there next to the negative, and we end up with negative 10 as our answer. Okay, so I have kind of a big problem here, and I had to shrink the font down actually just to make it fit on the screen, so hopefully it's not cut off. So we have 4 plus negative 7 plus 3 plus negative 8 plus 2 plus negative 9 plus 1 plus negative 10. So let's put all the positive numbers together. So 4 plus 3 plus 2 plus 1. Let's put all the negatives together. Negative 7 plus negative 8 plus negative 9 plus negative 10. Okay, so 4 plus 3 is 7. 7 plus 2 is 9. 9 plus 1 is 10. The negatives, again, the answer will be negative. And just go through and add. Think about each one as if they were a positive number, right? We're just working with absolute values. So what's 7 plus 8? That's 15. Then 15 plus 9 is 24. And again, for the sake of completeness, let me do this using a vertical addition. 5 plus 9 is 14. Carry the 1. 1 plus 1 is 2. So that's 24. And then lastly, you're adding 10. So that would be 34. So we ended up with negative 34 here. And again, for the sake of completeness, let me just do that using a vertical addition. So 24 plus 10. 4 plus 0 is 4. 2 plus 1 is 3. Okay, so when I slap that next to the negative, again, I end up with negative 34. So now we've got this problem down to just two numbers, 10 and negative 34. So when you think about it, the absolute value of 10 is 10. The absolute value of negative 34 is 34. So we're going to use a negative in our answer, right? Because negative 34 has a larger absolute value. And then we're just going to subtract the larger absolute value minus the smaller absolute value. So 34 minus 10. 4 minus 0 is 4. 3 minus 1 is 2. So we end up with 24 there. But again, remember, we have to attach that negative to it, and we end up with negative 24 as our answer. Hello and welcome to Pre-Algebra Practice Set number 20. And in this video, we're going to look at some additional practice problems for our lesson on subtracting integers. Okay, we just want to perform each subtraction. So we're going to begin today with negative 6 minus 3. And what I told you in the lesson was you're going to take your subtraction problems and change them into related addition problems. So negative 6 stays the same. You change your subtraction to addition, and then you change your number that's being subtracted away, which in this case is 3, into its opposite. So the opposite of 3 is negative 3. So if I'm subtracting away 3, it's the same as adding negative 3. So we've changed this problem to negative 6 plus negative 3. That's pretty easy to do. We just keep the sign that's common to both. So the answer will be negative. And then we just add our absolute values, right? So we're going to add 6 plus 3, and that's 9. So our answer here is negative 9. Well, What about negative 8 minus 2? Well, again, we're going to change this to a related addition problem. Keep this negative 8 the same. Okay, your leftmost number stays the same. Change your subtraction to addition, and change the number being subtracted away, which in this case is 2, into its opposite. So the opposite of 2 is negative 2. And so now we have an addition problem, negative 8 plus negative 2. So the signs are the same, so the answer will have a negative sign. And we just add the absolute values. So 8 plus 2 is 10. So our answer here will be negative 10. What about negative 7 minus a negative 5? So as I taught you in the lesson, when you see minus a negative, it's plus a positive. Okay? Minus a negative is plus a positive. So negative 7 will remain unchanged. Change your subtraction to addition and change the number being subtracted away. In this case, it's a negative 5 into its opposite. The opposite of negative 5 is positive 5. Again, subtracting away a negative 5 is the same as adding a positive 5. Subtract away a negative, you're adding a positive. Okay, so negative 7 plus 5. Use the sign from the number with the larger absolute value. In this case, that's going to be negative 7. Right? So the sign will be negative. The absolute value of negative 7 is 7. The absolute value of 5 is 5. So now we subtract absolute values. Right? We take the larger, subtract away the smaller. So you'd have 7 minus 5, and that's 2. You attach that to that negative, and your answer here is negative 2. Okay, what about negative 4 minus 3? Again, leave this leftmost number unchanged, so negative 4. Change your subtraction to addition. Change your number 3, that's being subtracted away, into its opposite. The opposite of 3 is negative 3. So now we have negative 4 plus negative 3. Again, keep the common sign in the answer, so the answer is negative. And just add the absolute values of the numbers. So 4 plus 3 is 7. So this ends up being negative 7. What about 9 minus 13? Again, keep this leftmost number unchanged. Change your subtraction to addition. And change 13, the number that's being subtracted away, into its opposite. So now we have 9 plus negative 13. So we use the sign from the number with the larger absolute value. The absolute value of negative 13 is 13. The absolute value of 9 is 9. So negative 13 has a larger absolute value, so the answer will be negative. And now we just subtract the absolute values, right? We take 13, which is the larger, and we subtract away 9, which is the smaller. 13 minus 9 is 4, so our answer here will just be negative 4. Okay, when we subtract integers and there's more than 2 involved, you basically use the same procedure. When you're subtracting away a number, you're just going to change that subtraction to addition of the opposite. So if we have negative 8 minus a negative 1 minus 5, negative 8 stays the same. But then I'm subtracting away a negative 1. Change that to addition of the opposite. So I'm adding a positive 1. I'm subtracting away 5. Change that to addition of the opposite. So plus a negative 5. So now I have 3 numbers involved. 2 of them have the same sign. Let's add those first. So negative 8 plus negative 5 plus 1. What's negative 8 plus negative 5? Use the common sign in the answer. So that would be negative. And then just do the absolute values. So 8 plus 5 is 13. So this would be negative 13 and then plus 1. All right, so to solve this problem, again, use the sign from the number with the larger absolute value. The absolute value of negative 13 is 13. The absolute value of 1 is 1. So our answer will be negative. And then just subtract the absolute values, right? You do the larger minus the smaller. So you're going to do 13 minus 1, and that's 12. So we end up with negative 12 as our answer. Okay, what about negative 3 minus 7 minus negative 5 minus 16? All right, so the first number, or the leftmost number, stays the same. So negative 3. I'm subtracting away 7, so I'm going to change that to addition of the opposite, so plus a negative 7. I'm subtracting away a negative 5, so I'm going to add the opposite of negative 5, which is positive 5. Again, when you see minus a negative, you should be thinking plus a positive. Then I'm subtracting away 16, so I'm going to change that to plus a negative 16. So I have 3 numbers here with a negative sign, and so I'm going to add those 3 together first. So I know the result will be negative, and I'm just going to add absolute values. So 3 plus 7 would be 10, and then 10 plus 16, 0 plus 6 is 6, 1 plus 1 is 2. So we'd end up with negative 26 and then plus 5. Okay, so for this one, again, we use the sign from the number with the larger absolute value. So in this case, that's going to be negative 26, right? The absolute value of negative 26 is 26. The absolute value of 5 is 5. So our sign will be negative. Okay, now we want to subtract absolute values. We do the larger minus the smaller. So we're going to do 26 minus 5. 6 minus 5 is 1. Bring down the 2. So we're going to end up with negative 21. Okay, negative 21 as our answer. All right, for the final problem, we have negative 5 minus 12 minus 6 minus a negative 10. All right, so starting out all the way on the left here, this negative 5 is going to remain unchanged. Then I'm subtracting away 12, so that's the same thing as adding a negative 12. I'm subtracting away 6. That's the same thing as adding a negative 6. And then I'm subtracting away a negative 10. That's the same thing as adding a positive 10. Again, subtract away a negative, add a positive. All right, so again, we have the same scenario where 3 of the numbers are negatives. Let's just add those 3 together first. We know the answer will be negative. So just think about the absolute values here. 5 plus 12 is 17. And then 17 plus 6. 7 plus 6 is 13. Carry the 1. 1 plus 1 is 2. So the result is going to be negative 23. Then plus 10. Okay. Again, to solve this, use the sign from the number with the larger absolute value. In this case, that's going to be negative 23. Right? The answer is going to be negative. The absolute value of negative 23 is 23. The absolute value of 10 is 10. So now we subtract the absolute values. We'll do 23, which is the larger, minus 10, which is the smaller. So 23 minus 10, 3 minus 0 is 3, 2 minus 1 is 1, gives us 13. So we end up with negative 13 as our answer. Hello, and welcome to Pre-Algebra Test Section 1 on subtracting integers. All right, we just want to perform each subtraction, and we're going to start out with 6 minus 8. So what I told you in the lesson was, essentially we're going to transform our subtraction problems into a related addition problem. So the way you do that is you keep the leftmost number unchanged, you change your subtraction to addition, and then you change your number that's being subtracted away, which in this case is 8, into its opposite. So the opposite of 8 is negative 8. So subtracting away positive 8 is the same thing as adding negative 8. So now that we have a related addition problem, we can just perform this with our rules for adding integers. So if we have 6 plus negative 8, the result will be negative, right? Because negative 8 has a larger absolute value. And then we would just subtract 8 minus 6. The absolute value of negative 8 is 8. We would take away the absolute value of 6, which is 6. 8 minus 6 is 2. So we end up with negative 2 as our answer. What about 11 minus 17? Well, again, I'm going to leave the first number here, or the leftmost number, unchanged. I'm going to change my subtraction to addition, and then I'm going to change 17 into its opposite. So again, subtracting away 17 is the same as adding a negative 17. Now, if I look at these two numbers, I can see that the absolute value of negative 17 is larger, so the sign is going to be negative. And then I just want to subtract absolute values. So the absolute value of negative 17 is 17. The absolute value of 11 is 11. I would do 17 minus 11. That's 6. And so I'd end up with negative 6 as my answer. Okay, what about negative 15 minus 9? Well, again, this leftmost number is going to stay unchanged. And then I'm subtracting away 9, so that's the same thing as adding a negative 9. So if I have negative 15 plus a negative 9, the sign here is the same. In each case, I have a negative. So the answer will be negative. And then I just add absolute values. So I just pretend both those numbers are positive. I would say, well, what is 15 plus 9? 5 plus 9 is 14. 1 plus 1 is 2. So I drag this over here, and I end up with negative 24 as my answer. What about negative 12 minus 22? Well, again, keep this leftmost number the same. Change your subtraction to addition. Change 22, the number that you're subtracting away, into its opposite. So subtracting away 22, again, is the same as adding negative 22. All right, so to do this, we have the same sign. So the answer will be negative. And then we just want to add absolute values. So we do 12 plus 22. 2 plus 2 is 4. 1 plus 2 is 3. So we drag this up here, and we'd end up with negative 34 as our answer. Okay, for the last problem, we have negative 14 minus 115. So again, this leftmost part here stays the same. Change your subtraction to addition, and change this 115 here, the number that's being subtracted away, into its opposite. So it'll become negative 115. And now we just want to add. Again, the sign will be negative because we have our two numbers that are being added as negative. And then we just add absolute values. So what is 115 plus 14? 5 plus 4 is 9. 1 plus 1 is 2. Bring down the 1. You can kind of send this over here and say we have a result of negative 129. Hello and welcome to Pre-Algebra Test Section 2 on subtracting integers. Okay, so we want to perform each subtraction, and we're going to start out with negative 7 minus 8. So what we're going to do here is we're going to leave the leftmost number, which in this case is negative 7, unchanged. I'm going to change my subtraction operation to addition, and then I'm going to change this number 8, the number that's being subtracted away, into its opposite. So I've converted this to a related addition problem. Negative 7 minus 8 is the same as negative 7 plus negative 8. Subtracting away 8 is the same as adding a negative 8. So now we can just add these two integers. They have the same sign, so the answer will be negative, right? We use the common sign in the answer. Now we just add absolute values. What is 7 plus 8? Well, that's 15. So our answer here will just be negative 15. What about a negative 4 minus a negative 2? Now I taught you in the lesson when you see minus a negative, you think plus a positive. So negative 4 will stay the same. Change your subtraction to addition. Change the number being subtracted away. In this case, it's a negative 2 into its opposite. The opposite of negative 2 is positive 2. Again, if you see minus a negative, think plus a positive. So what is negative 4 plus 2? So when we have different signs, again, we think about the absolute value of each. The absolute value of negative 4 is 4. The absolute value of 2 is 2. So negative 4 has a larger absolute value, so we use its sign in the answer. So the answer there is negative. Now we just subtract 4 minus 2, right? We take the larger absolute value, subtract away the smaller. So 4 minus 2 is 2. Slap that negative on there, and we end up with negative 2 as our answer. Okay, what about negative 1 minus 99? So again, I keep the leftmost part unchanged. So negative 1 is unchanged. Change the subtraction to addition, and then change 99, the number being subtracted away, into its opposite. So what do we do now? Well, we have a common sign. We have a negative here and here, so the answer will be negative. And then I just add absolute values. What is 1 plus 99? Well, that's 100. So attach that with the negative, and you get negative 100 as your answer. What if we look at negative 70 minus a negative 12? Again, if you think about minus a negative, you should be saying plus a positive. So the negative 70, the leftmost part, stays the same. The minus sign becomes a plus, and then the opposite of negative 12 is positive 12. Again, minus a negative is plus a positive. Okay, so if we add these two numbers together, the sign will be from the number with the larger absolute value. In this case, the sign will be from negative 70, right? The absolute value of negative 70 is 70. The absolute value of 12 is 12. So our sign will be negative. Now we just subtract absolute values, right? We'll do 70 minus 12. We do the larger minus the smaller. So 70 minus 12. 10 minus 2 is 8. 6 minus 1 is 5. Drag this guy up here, and we end up with negative 58 as our answer. What about negative 18 minus a negative 13? Again, we have a scenario where we have minus a negative, so we should be thinking about plus a positive. So this leftmost part here stays unchanged. Change the subtraction to addition, and change the negative 13 to its opposite. The opposite of negative 13 is 13. Okay, so we use the sign from the number with the larger absolute value, and the absolute value of negative 18 is 18. The absolute value of 13 is 13. So we'll use the sign from negative 18. So the answer will be negative. And now we just subtract absolute values. So we'll do the larger, which is 18, minus the smaller, which is 13. 18 minus 13 is 5. So put that next to the negative, and our answer here is negative 5. Hello and welcome to Pre-Algebra Test Section 3 on subtracting integers. All right, we just want to perform each subtraction. And essentially what we're doing here is Every time we're subtracting away a number, we're changing it into addition of the opposite. So for example, in this problem, we have 3 minus 8 minus 6 minus 17. So the first number, the 3, is going to stay the same. And then I'm subtracting away 8, so I'm going to change that to adding negative 8. Okay, if I'm subtracting away 8, it's the same as adding the opposite of 8, which is negative 8. Subtracting away 6, I'm going to change that to plus negative 6. Continuing, I'm subtracting away 17, so I'm going to change that to plus negative 17. Okay, so 3 of these numbers have the same sign. So let's add those together first. So negative 8 plus negative 6 plus negative 17. We know the result would be negative. And then we can just add absolute values. So 8 plus 6 is 14. And then 14 plus 17. 4 plus 7 is 11. 1 plus 1 is 2. Plus 1 is 3. So this would be negative 31. And so now we just have 3 plus negative 31. So we use the sign from the number with the larger absolute value. The absolute value of negative 31 is 31. The absolute value of 3 is 3. So we're going to use a negative sign, right? Because negative 31 has a larger absolute value. So the answer will be negative. And then we're just going to subtract absolute values. So we would do 31, which is the larger, minus 3, which is the smaller. 11 minus 3 is 8, and then bring down the 2. So we'd end up with a negative 28 as our answer. Okay, what about 5 minus 3 minus 7 minus 11? This first number 5 will stay unchanged. Then I'm subtracting away 3, so I'm going to put plus negative 3. I'm subtracting away 7, so I'm going to put plus negative 7. I'm subtracting away 11, so I'm going to put plus negative 11. So just like we had in the last problem, 3 of these numbers have the same sign, so let's add those together first. So we know the result will be negative, right, because that's the common sign. And then we just add absolute values. 3 plus 7 is 10, then plus 11 is 21. So we'd end up with negative 21 here. And now we have 5 plus negative 21. Again, to do that, think about the absolute value of each number. The absolute value of 5 is 5. The absolute value of negative 21 is 21. So we use the sign from the number that has the larger absolute value. So we're going to use the sign from negative 21. So our answer here is going to be negative. And then we just want to subtract absolute values. So we're going to do the larger, which is 21, minus the smaller, which is 5. 11 minus 5 is 6. Bring down the 1, and we end up with negative 16 as our answer. All right, for the final problem, we have negative 7 minus a negative 9 minus 4 minus 9. So negative 7 stays the same. If I'm subtracting away a negative, I'm adding a positive, right? Think about changing the subtraction to addition and then changing what's being subtracted away. In this case, that's negative 9 to its opposite. The opposite of negative 9 is positive 9. Subtract away 4, that's the same as adding negative 4. Subtract away 9, that's the same as adding negative 9. So we have negative 7, negative 4, and negative 9. They're all negative. Well, one thing I can do to make this problem easier is I can notice that 9 and negative 9 are opposites. When opposites are added, their result is 0. So if I want to make this problem super easy, just reorder this addition and say, okay, I'm going to put negative 7 plus negative 4 plus 9 plus negative 9. Add these two parts together first, and the result is 0. So I'd have negative 7 plus negative 4, and I could write plus 0 if I want to, but you don't have to because adding 0 doesn't change anything. So I just have negative 7 plus negative 4. So I use the common sign in the answer, that's negative, and then I just add the absolute values. So 7 plus 4 is 11, so I end up with negative 11 as my answer. Hello and welcome to Pre-Algebra Test Section 4 on subtracting integers. Okay, we just want to perform each subtraction. So we're going to start out with negative 15 minus a negative 25 minus 17 minus a negative 8 minus 4. So what we're going to do is we're going to change each subtraction operation into a related addition operation. And so this negative 15 will stay unchanged. And if I'm subtracting away a negative 25, that's the same as adding a positive 25. If I'm subtracting away 17, that's the same as adding a negative 17. If I'm subtracting away a negative 8, that's the same as adding a positive 8. If I'm subtracting away a 4, That's the same as adding a -4. So essentially all I did was I changed the subtraction to addition, and I changed what was being subtracted away to its opposite. The opposite of -25 is 25. The opposite of 17 is -17. The opposite of -8 is 8. The opposite of 4 is -4. That's all I did. Okay, so now what I want to do is let's rewrite this as -15 plus -17 plus -4 plus 25 plus 8. So I put my numbers with common signs next to each other. So these three numbers are negative, these two numbers are positive. Let's add our negatives first. So the sign will be negative, and then you can just add the absolute values. So let me scroll down, and we'll just do that using vertical addition. So 15, 17, and 4. 5 plus 7 is 12. 12 plus 4 is 16. 1 plus 1 is 2. Plus 1 is 3. So this will be -36. And then over here I have 25 plus 8. So 25 plus 8. 5 plus 8 is 13. 1 plus 2 is 3. So we'll end up with 33 as our answer for that. And we have one final part here. We want to add -36 and 33. So when we add two numbers with different signs, we want to use the sign of the number with the larger absolute value. So -36 has an absolute value of 36. 33 has an absolute value of 33. So -36 has a larger absolute value, so we're going to use its sign in the answer. So the answer is going to be negative. Then you just subtract absolute values. You take the larger, which in this case is 36, and you subtract away the smaller, which in this case is 33. 6 minus 3 is 3. 3 minus 3 is 0. So we end up with 3. We attach that negative to it, and our answer is -3. Okay, for the last problem, we have -27 minus -103 minus 81 minus 54 minus a -13. All right, so this first number, or the leftmost number, stays unchanged. I'm subtracting away a -103. That's the same as adding a +103. Again, the subtraction becomes addition, and we change the number that's being subtracted away into its opposite. The opposite of -103 is 103. Same thing for this. Change the subtraction here to addition. 81 will become its opposite. The opposite of 81 is -81. Subtracting away 54. So we'll put plus -54. Subtracting away a -13. So we're adding a +13. So let's reorder this. I'm going to put -27 plus -81 plus -54. Again, I put my three numbers that had the same sign next to each other. You don't have to do that, but it's a little bit easier to me to do it. Then I'll put plus 103, then plus 13. Okay, so now we know that if we add -27, -81, and -54, the result will be negative. So now we can just focus on the absolute values. We'll do 27 plus 81 plus 54. 7 plus 1 is 8. 8 plus 4 is 12. 1 plus 2 is 3. 3 plus 8 is 11. 11 plus 5 is 16. So that would give me -162. Now I have 103 plus 13. So 103, 13. 3 plus 3 is 6. 0 plus 1 is 1. Bring down the 1. I have 116 there. So let's write that guy right here. So plus 116. And again, if we have an addition problem where the signs are different, we're going to use the sign from the number with the larger absolute value. So the absolute value of -162 is 162. The absolute value of 116 is 116. So we're going to use the sign from -162. All right, so the result is going to be negative. And then we just do a basic subtraction. We do the larger absolute value, which is 162, minus the smaller absolute value, which is 116. We'll borrow here. 12 minus 6 is 6. 5 minus 1 is 4. 1 minus 1 is 0. So drag that up here, and we end up with -46 as our answer. Hello and welcome to Pre-Algebra Test Section 5 on subtracting integers. All right, so we just want to perform each subtraction. And what we're going to do for these problems is we're going to change the subtraction operation to addition of the opposite. So we have -90 minus 27 minus -7 minus 14 minus -28 minus 11. So this first number is going to stay the same. Now I'm subtracting away 27. That's the same thing as adding negative 27. I'm subtracting away negative 7. That's the same thing as adding positive 7. Subtracting away a negative is adding a positive. I'm subtracting away 14. That's the same thing as adding negative 14. Then I'm subtracting away a negative 28. That's the same thing as adding a positive 28. And then lastly, I'm subtracting away 11. That's the same thing as adding a negative 11. So let me continue that down here. Plus negative 11. And what I'm going to do now is I'm going to reorder this addition to where all my negative numbers are next to each other and all my positive numbers are next to each other. And I just like to do that for myself. It keeps me organized. So I'll have negative 90 plus negative 27 plus negative 14 plus negative 11. Now I have my two positive numbers, so plus 28 and then plus 7. And remember, because we're using addition here, addition is commutative, and we can add in any order that we'd like. Okay, so let's start by adding the negative numbers. So that's these here. And we know the result's going to be negative. So we're just going to do a vertical addition with the absolute values. So 90, 27, 14, and 11. Let's add those. So 0 plus 7 is 7. 7 plus 4 is 11. 11 plus 1 is 12. 1 plus 9 is 10. 10 plus 2 is 12. 12 plus 1 is 13. 13 plus 1 is 14. So we get 142. So we'll bring that over. And remember, this will be a negative 142 because we're working with negative numbers. So then plus, next we have 28 plus 7. A lot of us can do that in our head because we watch football. We know that if a team has 28 and they score a touchdown and kick an extra point, they get another 7 points and they get 35. But we can do that using a vertical addition. 8 plus 7 is 15. 1 plus 2 is 3. Again, 35. All right. So now we have negative 142 plus 35. So we're going to use the sign from the number with the larger absolute value. And obviously that's negative 142. Right? So the sign of the answer will be negative. And then we're just going to subtract absolute values. So the absolute value of negative 142 is 142. The absolute value of 35 is 35. We subtract the bigger number, 142, minus the smaller number, 35. And so we borrow here. 12 minus 5 is 7. 3 minus 3 is 0. Bring down the 1. So we get negative 107 as our answer. Okay, let's take a look at negative 45, minus 300, minus negative 4, minus negative 2, minus 39, minus negative 73. Okay, so we're going to change this to a related addition problem. So negative 45 stays the same. And I'm subtracting away 300, so I can write that as plus negative 300. I'm subtracting away a negative 4, okay? Minus a negative is plus a positive. So subtracting away negative 4 is the same as plus positive 4. I'm subtracting away a negative 2, that's the same as plus positive 2. I'm subtracting away 39, that's the same as plus negative 39. And then lastly, I'm subtracting away a negative 73. That's the same as adding a positive 73. Okay, now going through here, let's write this as negative 45 plus negative 300 plus negative 39, then plus 4 plus 2 plus 73. And all I did was I reordered my addition to where my like signs were next to each other. So let's add the negatives here. And we know that the result will be negative. And now we can just worry about the absolute values. So I'll do that using a vertical addition. So 300, 45, and 39. 0 plus 5 is 5, plus 9 is 14. 1 plus 0 is 1, plus 4 is 5, plus 3 is 8. Bring down the 3. So you'd have negative 384. Then we have 4 plus 2 plus 73. We can pretty much do that in our head. 4 plus 2 is 6. 6 plus 73 is 79. So plus 79. Okay. So now, when we add two numbers with different signs, again, we use the sign from the number with the larger absolute value. So negative 384 has an absolute value of 384. 79 has an absolute value of 79. So I'm going to use the sign from negative 384. It has a larger absolute value. So the sign of the answer will be negative. And then I just want to subtract. I want to do the larger absolute value, which is 384, minus the smaller absolute value, which is 79. So I'll borrow here. 14 minus 9 is 5. 7 minus 7 is 0. Bring down the 3. And we get 305. Drag that over here. And remember, it's negative, right? We attach the negative to it. And we end up with negative 305 as our answer. Hello and welcome to Pre-Algebra Practice Set 21. And in this video, we're going to look at some additional practice problems for our lesson on multiplying and dividing integers. So we're going to start out with some multiplication problems, and we want to just find each product. So before we actually begin, let me refresh your memory on how we perform a multiplication when there's integers. So essentially, you're going to figure out what the sign is going to be first. And to do that, you have a basic rule. If the signs are the same, the answer is positive. If the signs are different, the answer is negative. Once you do that, you just multiply the absolute values of the numbers. Now, if I start out with something like negative 6 times negative 7, the signs are the same. I have a negative times a negative. So the signs are the same, the answer is positive. Now, I just work with the absolute values. So 6 times 7 would give me 42. So the answer here would be positive 42, or just 42. Next, I have negative 4 times 2. Now the signs here are different. I have a negative times a positive. So the answer will be negative. And now I just multiply absolute values. So I would do 4 times 2, and that's 8. So my answer here is negative 8. What about 3 times negative 8? Well, I have a positive times a negative. So the signs are different, so the answer is negative. Then I would just do 3 times 8, that's 24. So my answer here would be negative 24. Okay, for the next problem, we have 12 times negative 10. So we have a positive times a negative. Positive times negative gives me a negative, right? If the signs are different, I have a negative result. Now I just multiply the absolute values. So 12 times 10 would be 120. Right? So this would give me negative 120. What about negative 1 times negative 14? Negative times negative is positive. Right? If the signs are the same, okay, if the signs are the same, the answer is positive. Then you just do 1 times 14, and that's 14. Okay, what about 5 times negative 2? So we have a positive times a negative. So the signs here are different. So I'm going to get a negative, right? So 5 times 2 then would be 10, and the answer would be negative 10. Okay, then let's look at negative 18 times negative 20. So we have a negative times a negative. That's going to give us a positive. And then we would just do 18 times 20. Now, a lot of you might set up a vertical multiplication for that. But again, you can use your trick for trailing zeros. Think about 18 times 2. That's 36. And then you're going to attach one trailing zero to the end of that. So we end up with a positive 360. Okay, now let's look at some problems that involve more than two integers. So we'll start out with 3 times 6 times negative 8. So for these problems, kind of the fastest way to do it would be to think about what's my sign going to be first. Now, I gave you a little trick for that in the lesson. If the number of negative numbers you have involved is an even number, meaning it's a number that is divisible by 2. Okay, you divide by 2, you get no remainder. Then the result will be positive. If it's odd, okay, meaning it's not divisible by 2, you divide by 2, you get a remainder, then the answer is negative. Now in this case, this 3 times 6 times negative 8, we have one negative value. 1 is an odd number. It is an odd number. It's not divisible by 2. So our answer here will be negative. Now we can just pretend all the numbers are positive, right? We can just work with the absolute values. And 3 times 6 would be 18. And then you'd multiply 18 times 8. 18 times 8. 8 times 8 is 64. 8 times 1 is 8, plus 6 is 14. So drag that back up there. And we end up with negative 144 as our answer. Okay, for the next one, we have negative 1 times negative 2 times 7. So I have two negative numbers involved. 2 is an even number, right? It is divisible by 2. 2 divided by 2 is 1, no remainder. So the answer here will be positive. 1 times 2 times 7 is what we would do next, right? We just think about the numbers as if they're positive. 1 times 2 is 2. 2 times 7 is 14. So your answer here would be 14. Okay, for the next one, let's look at negative 15 times 30 times negative 1 times 2. So I have two negative numbers involved. 2 is an even number, so my answer is going to be positive. Now we just multiply the absolute values of the numbers. So think about 15 times 30 times 1 times 2. So I'm going to save the multiplication times 30 till last, because that's the toughest. So I'm going to reorder this. Put 15 times 1 times 2 times 30. Remember, with multiplication, you can reorder it as much as you want. That is perfectly legal. So 15 times 1 is 15, then times 2 is 30. So really, I could just think about this problem as 30 times 30. And that's easy to do because we have trailing zeros. You would do 3 times 3, that's 9, and then attach 2 trailing zeros, so you end up with 900. So bring that guy up here. Our answer is going to be positive 900. Okay, for the next one, let's look at 8 times negative 3 times negative 40 times 50 times negative 5. Okay, so we have 3 negative numbers involved here. 3 is an odd number, so my answer is going to be negative. Now I can just work with the absolute values. So I have 8 times 3 times 40 times 50 times 5. So I'm going to leave these numbers with trailing zeros to the end. So let me rewrite this as times 5 times 40 times 50. Okay, so 8 times 3 is 24. 24 times 5 is 120. So we'd have 120 times 40 times 50. So if I'm multiplying, and again, there's trailing zeros involved, you can multiply the non-zero numbers. So 12 times 4 would be 48. And then attach 2 trailing zeros. So 4,800 or 4,800. And then we still have to multiply times 50. So 4,800 times 50. So we do 48 times 5. 48 times 5. 5 times 8 is 40. 5 times 4 is 20. Plus 4 is 24. So that's 240. And then we're going to attach 1, 2, 3 trailing zeros. 2, 3. To get 240,000. So we'll come back up here. Remember, the result was negative. We already figured that out. And then we found that multiplying the absolute values gave us 240,000. So our answer for this problem is negative 240,000. Okay, let's practice a little bit of division. So we want to find each quotient. So we have negative 12 divided by positive 12. So again, the sign rules for division are the same as for multiplication. So a negative divided by a positive, the signs are different, so the answer is negative. And then you just work with the absolute values. So 12 divided by 12 would just be 1. So the answer here would be negative 1. Okay, the next one is negative 50 divided by negative 25. So negative divided by negative is positive. Again, the signs are the same. The answer is positive. And then 50 divided by 25 is 2. So we just get positive 2. Now let's look at 45 divided by negative 9. So we have a positive divided by a negative. That's a negative. And then we do 45 divided by 9, and that's 5. So we get negative 5 as our answer there. Okay, now we have negative 36 divided by negative 6. So we have a negative divided by a negative. That's a positive. And then we just do 36 divided by 6, and that's 6. Right? So we get positive 6 as our answer. And then lastly, we have 128 divided by negative 64. So 128 divided by negative 64. Positive divided by negative is negative. And then 128 divided by 64 is 2. So we'd end up with negative 2 as our answer. Hello and welcome to Pre-Algebra Test Section 1 on multiplying and dividing integers. So we want to just find each product. All right, so we're going to begin with negative 3 times negative 7. And what I taught you in the lesson is you figure out your sign first, and then you multiply the absolute values. Here we have a negative times a negative. So when we have the same signs, right, we have a negative times a negative, that's the same, you get a positive result. So the answer will be positive. And then we just think about the absolute values. So what is 3 times 7? That's 21. So negative 3 times negative 7 is positive 21. Next, we have 8 times negative 9. So to figure out our sign, we think about the fact that we have a positive times a negative. So if we have different signs, the result is negative. Then you just work with the absolute values. So 8 times 9 would be 72. Put that behind the negative sign, and we get an answer of negative 72. What about 12 times negative 10,000? Well, we have a positive times a negative, so that's a negative. And then for 12 times 10,000, use your trick for trailing zeros. You're going to do 12 times 1, that's 12, and then attach 1, 2, 3, 4 trailing zeros. So 1, 2, 3, 4, and put a comma there. You end up with negative 120,000. Next, let's look at negative 24 times negative 4. So negative times negative is positive. And then what is 24 times 4? 4 times 4 is 16. 4 times 2 is 8. Plus 1 is 9. So we get 96 there. So this will be positive 96. Okay, for the last problem, we have negative 18 times 5. So negative times positive is negative. And then we just do 18 times 5. 18 times 5. 5 times 8 is 40. 5 times 1 is 5. Plus 4 is 9. So that gives me 90. So we'll put that behind that negative sign. And we end up with negative 90 as our answer. Hello and welcome to Pre-Algebra Test Section 2 on multiplying and dividing integers. Okay, so we want to just find each product. So we're going to start out with negative 13 times 9. So as I taught you in the lesson, when you multiply integers, you first figure out what your sign is going to be. Then you just multiply the absolute values. So for a negative times a positive, basically having different signs involved, you're going to get a negative. So once we know the answer is negative, we can just pretend we have 13 times 9. So what is 13 times 9? 9 times 3 is 27. 9 times 1 is 9, plus 2 is 11. So this would give us 117. Now attach it to that negative there, and we get an answer of negative 117. Let's look at 100 times negative 151. Positive times negative gives me a negative. Again, if your signs are different, your result is negative. Now, what is 100 times 151? Use your rule for multiplying with trailing zeros. 151 times 1 is 151. And then attach 2 trailing zeros to the end. And we end up with negative 15,100. What about negative 205 times negative 10? Now we have a negative times another negative. So we have the same signs involved, so our answer is positive. Now just pretend the numbers are positive and multiply. What would 205 times 10 be? Well, again, use your trick for multiplying with trailing zeros. So it's 205, right? 205 times 1 is 205. And then attach 1 trailing zero to the end. And we end up with 2,050 as our answer. What about 28 times negative 2? Well, we have a positive times a negative. So we have different signs involved. So we know this is negative. And then we would just think about 28 times 2, and that's 56. So we'd end up with negative 56 as our answer. Okay, for the final problem, we have negative 11 times negative 7. So we have a negative times another negative. Same signs, the answer is positive. Then you just multiply with the absolute values. So what is 11 times 7? That's 77. So our answer here is just 77. Hello and welcome to Pre-Algebra Test Section 3 on multiplying and dividing integers. So for our problems, we want to find each product. We're going to start out with 6 times negative 3 times 2. So when we multiply more than two integers, we can use a little trick. So we would count the number of negative numbers involved in the problem. So in this case, there's only one, right? We just have a negative 3. The 6 and the 2 are both positive. If the number of negative numbers involved in your problem is an even amount, again, that means it's divisible by 2, your answer is positive. If it's an odd amount, meaning again that it's not divisible by 2, your answer is negative. Here we only have 1. 1 is an odd number, so the answer is negative. Once you figure out the sign, you can go through and just multiply the absolute values, right? So just pretend the numbers are positive. So you would just do 6 times 3, that's 18, then times 2, that's 36, to give you negative 36 as your answer. For this problem, we have negative 8 times 7 times -4 times -1. So we have 1, 2, 3 negatives involved. 3 is an odd number, so the answer is negative. Now we just go through and multiply the absolute values. So we have 8 times 7, that's 56, then times 4. So think about 56 times 4. 4 times 6 is 24. 4 times 5 is 20, plus 2 is 22. So we would essentially have 224 times 1, which is just 224. So now we attach that to the negative sign, and we get an answer of negative 224. Okay, now let's look at -1 times 5 times -12 times 9. So we have 2 negatives involved. 2 is an even number, so the result is positive. Now we can think about multiplying the absolute values. So 1 times 5 is 5. 5 times 12 is 60. And then 60 times 9 I can do by using my trick for trailing zeros. I would do 6 times 9, that's 54, and then I would attach 1 trailing zero to the end. So this is going to be positive 540 for our answer. Okay, let's take a look at 17 times -3 times 1 times 0 times -81. Now, most of you are going to start this problem by saying, okay, I have 2 negatives involved. 2 is an even number, so this is positive. The reason you don't do that here is because you have a 0 as a factor. Whenever you have 0 as a factor, the answer is just 0. Okay? 0 is also not positive or negative, so you don't need a positive or negative sign. It's just 0. Now, one of the things you can think about here is that whatever the result is of the multiplication through here, once you multiply by 0, you're done. Right? The answer is 0. And then 0 times anything after that is always 0. So anytime you have 0 as a factor, and you just have multiplication involved, again, your answer is 0. Okay, let's take a look at the last one. We have 11 times 10 times -3 times -1. So we have 2 negatives involved. 2 is an even number, so the answer will be positive. And then we just multiply the absolute values. So 11 times 10 I can think of as 11 times 1. That's 11. Put a 0 at the end. It's 110. Then I'd multiply times 3 times 1. So 110 times 3 times 1. So 110 times 3, I can think about that as 11 times 3, that's 33. Attach a 0 to the end. Then this 330 times 1 would just still be 330. Okay, so my answer here for this problem is going to be 330. Hello and welcome to Pre-Algebra Test Section 4 on multiplying and dividing integers. All right, so we just want to find each quotient. And to begin, we have -3 divided by 1. Now, when we divide integers, we use the same sign rules as when we multiply integers. So here we have a negative divided by a positive. We have different signs, so the result is negative. Once you figure out your sign, you just divide the absolute values. So you just think about 3 divided by 1 is 3. Put that behind your negative sign, and you get -3 for your answer. Okay, next we have -4 divided by -2. So if I have a negative divided by another negative, the answer will be positive. Right? If I have the same signs, right, a negative and a negative, the answer is positive. So then I think about the absolute values. 4 divided by 2 is just 2. So the answer here is just 2 or positive 2. Next, let's do 10 divided by -5. We have a positive divided by a negative. So different signs involved, we're going to have a negative result. And then you just do 10 divided by 5, and that's 2. So we get -2 as our answer. Now we have 25 divided by -5, and so we have a positive divided by a negative. Different signs, you get a negative result. Then we do 25 divided by 5, and that's 5. So we have -5 as our answer. Okay, for the final problem, we have -300 divided by -10. So we have a negative divided by another negative. We have the same signs, so the answer is positive. So now we just do 300 divided by 10, and that's going to give us 30. So we end up with positive 30 as our answer. Hello and welcome to Pre-Algebra Test Section 5 on multiplying and dividing integers. Okay, so we want to just find each quotient. And we're going to start out with -42 divided by -7. So what we're going to do here is figure out what our sign is first, and then we'll just divide the absolute values. So when we have a negative divided by another negative, the answer will be positive. Again, if you have the same signs, the answer is positive. If you have different signs, the answer is negative. So now that we know that the sign is positive, we just think about the absolute values now. So we would think about 42 divided by 7, that's 6. And we already know the answer was positive, so we get positive 6, or just 6, as our answer. Next, let's think about negative 81 divided by 9. So we have a negative divided by a positive. So we have different signs involved. The answer is negative. Now we would think about the absolute values. So 81 divided by 9 is 9. So our answer here is negative 9. Okay, now we have 200 divided by negative 5. So we have a positive divided by a negative. So positive divided by a negative. Again, different signs, you get a negative. Now what's 200 divided by 5? Some of you might need to do a long division for that. But basically if you think about what times 5 would give you 200, well, I know that 4 times 5 would give me 20, right? 4 times 5 equals 20. Now, thinking about the trailing 0 thing that we've learned, I have another 0 at the end of 20. I have 200, right, if I put a 0 there. So if instead of 4, I had a 40, okay, I had a 40, then this would be 200, right? Because I'd multiply 4 times 5 and get 20 and put a 0 at the end. So my answer here is that 200 divided by negative 5 is negative and then 40. We have 10,000 divided by negative 1,000. So we know the answer is negative, right? Positive divided by negative is negative. And then we think about, okay, what times 1,000 would give me 10,000? I can see that 1,000 has one less 0 than 10,000, right? So if I multiply, I'm going to multiply by a number that has 1 0 on it. So it'll be a 1 with 1 0. So that's the number 10, right? 10 times 1,000 would be 10,000. And so the answer here would be negative 10. All right, for the final problem, we have negative 45 divided by negative 15. And so negative divided by negative is positive. And then thinking about 45 divided by 15, some of us will need to do a long division for that, but really just think your way through it. So you have 45 divided by 15 equals what? So then what times 15, what number times 15 would equal 45? Well, just thinking about this using repeated addition, if I had 15 plus 15, that would be 2 times 15, that's 30. If I add 15 more to that, meaning 3 times 15, so 15 plus 15 plus 15, that's 45. That's exactly what I'm looking for. So it would be 3 times 15 to get to 45. So the answer here would be 3. Hello and welcome to Pre-Algebra Practice Set number 22. And in this video, we're going to look at some additional practice problems for our lesson on exponents with an integer base. Okay, so for our problems, we just want to evaluate. And we're going to start out with negative 1 raised to the power of 8. Now I want you to pay close attention here. We have parentheses around this number negative 1. So that means both the negative part and the 1 are raised to the power of 8. So essentially what I'd have here, if I went through this the long way, I'd have negative 1 times negative 1 times negative 1 times negative 1, and I'll continue this down here, times negative 1 times negative 1 times negative 1 times negative 1, right? 8 factors of negative 1. 1, 2, 3, 4, 5, 6, 7, 8. Now, from our knowledge of multiplying integers, I know that if I have an even number of negative factors, I'm going to get a positive result. So this would be positive, and I wouldn't need to think about the sign anymore. I could just multiply with the absolute values. So 8 factors of just 1 would give me a result of 1. I could multiply 1 times itself as many times as I want. I will always get 1 as a result. So that's pretty easy. So I'd end up with positive 1. But now the shortcut, let me just erase this real quick. The shortcut here is just to realize that, okay, if I have my negative number inside of a set of parentheses and I have an even exponent, the answer will be positive. Okay, the answer will be positive. Because again, I'm just going to have an even number of negative factors. Now the next thing is to think about what's the number part going to be? I got the sign, what's the number? Well, just thinking about the absolute value of this, it would just be 1. And I can think about, well, what is 8 factors of 1? Well, 8 factors of 1 would just be 1. So I'd end up with positive 1 as my answer. Now, you have to pay close attention, again, to whether or not you have parentheses around the number or not. If I had -1 to the 8th power written like this, I don't get the answer of 1. I get the answer of -1. And if you didn't watch the lesson, you might be saying, well, why is that the case? Go ahead and type this up on your calculator. Put parentheses around -1 and put in to the 8th power, you'll get 1. Don't put parentheses around -1 and put it to the 8th power and you'll get -1. And the reason for this is because I'm saying, hey, what's the opposite? What's the opposite of 1 raised to the 8th power? I could basically write this as -1 times 1 to the 8th power. And then we'd see that we'd have 1 to the 8th power is 1. So you'd have -1 times 1, and that would give you -1. So you have to pay close attention to whether or not you have parentheses around your base if the number is negative. If you don't, the answer is always going to be negative. If you do, the answer is positive if your exponent is even, like in this case. It's going to be negative if your exponent is odd, like in this case that we're going to get to in a second. So if we have -1 inside of parentheses raised to the 5th power, I would get a negative. And the reason for that is I'd have an odd number of negative factors that gives me a negative result. So this would be -1. Right? I know the sign would be negative, and then 1 to the 5th power is just 1, so I'd get -1. Here I have -1 to the 28th power. And again, it doesn't matter here that the exponent is even. If I don't have parentheses around the base, I'm going to get a negative result. That's just the way it works because I basically have -1 times 1 to the 28th power. This is a notational issue. Right? It'll come up. You have to pay close attention when you're working with these negative numbers. So I would have what? -1 times 1. 1 to the 28th power is just 1, and that gives me -1. Here we have -6 to the 4th power. -6 is not enclosed inside of a set of parentheses. So again, this can be written as -1 times 6 to the 4th power. And because of the order of operations, we do 6 to the 4th power first. That's 6 times 6, that's 36, times 6, that's 216, and then 216 times 6 is 1,296. So I'd have -1 times 1,296, which is -1,296. Again, I don't have parentheses around the base, so it doesn't matter that this exponent is even. I get a negative result either way. Now here's the same problem with a different notation. We have parentheses around -6 now, and it's raised to the 4th power. So this is -6 times -6 times -6 times -6. The negative and the 6 are being raised to the 4th power. So we'd have what? We'd have positive 1,296. Essentially, the sign now is determined by the exponent. How many negative factors are we going to have? Well, we have 4. That's an even number, so the answer is positive. And then the 6 to the 4th power part is the same. 6 to the 4th power, again, is 6 times 6, that's 36. Times 6, that's 216. Then times 6 one more time, which is 1,296. What about -3 cubed with no parentheses around the base? Well, in this case, again, if there's no parentheses around the base, it's always going to be negative. So the sign's negative, and then you can just think about what is 3 cubed? Well, 3 cubed is 3 times 3, that's 9. Then times 3, that's 27. So this is -27. But what's interesting here is that if I had parentheses in this case around -3, I'd still get a -27. And the reason for that is I'd have -3 times -3 times -3. I would have an odd number, right, 3. I'd have an odd number of negative factors, which gives me a negative result. So I get -27 here as well. And if this had been an even exponent, so for example, if we were working with the problem, let's say -3 to the 4th power like this, well, this part would be negative. We'd have negative, and then 3 to the 4th power. 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 81. So you'd have -81. And then when you put this inside of parentheses, now I'm thinking about, okay, well, this exponent is even, so I'd get a positive 81, right? Because I'd have an even number of negative factors. So that gives me a positive, and 3 to the 4th power is 81. So when this is even and it's inside of parentheses, you will get a positive result. When this is odd and inside of a set of parentheses, you will get a negative result. And when you don't have parentheses around your base and it's negative, you always get a negative result. Okay, let's think about negative 2 to the 7th power. So we have parentheses around the base here, but our exponent is odd. And when we have an exponent that's odd, we're going to get a negative result. So we just think about 2 to the 7th power now. 2 to the 7th power is 128. So we'd end up with negative 128 as our answer. What about negative 10 inside of a set of parentheses raised to the 6th power? Well, this is an even number here, and my negative 10 is inside of parentheses, so I'd have an even number of negative factors. That would give me a positive result. Now I just think about 10 to the 6th power. Remember your trick. If you have 10 to the 6th power, you write a 1 followed by 6 zeros. 1, 2, 3, 4, 5, 6. So that gives me positive 1 million. Next, we're going to look at negative 10 to the 4th power. But even though this is even, remember, we don't have parentheses around the base. So if there's no parentheses around the base, in this scenario, you're going to get a negative result. Because I'm saying, hey, what's the opposite of 10 to the 4th power? And the opposite of 10 to the 4th power, 10 to the 4th power is a 1 followed by 4 zeros. 1, 2, 3, 4. So this would be negative 10,000. Right? It'd just be the opposite of 10,000, which again is negative 10,000. Okay, now we're just going to determine if the sign will be positive or negative. So let's start out by looking at negative 51 squared. Notice how there's no parentheses around the base, and so the result will be negative. Next, we're going to look at negative 139 cubed. So we do have parentheses around the base here, but the exponent is odd. So that's going to give me a negative. I'd have an odd number of negative factors. That's going to give me a negative result. Okay, next let's look at negative 38 to the 4th power. Now notice how the negative 38 is enclosed inside of a set of parentheses. So now I'm looking at this exponent here. So the exponent is a 4. That's an even number. So if I had an even number of negative factors, the result would be positive. Okay, now we have negative 2 to the 8th power, and the negative 2 is enclosed inside of a set of parentheses. So I'd look at the exponent. So that's an 8. 8 is an even number, so my answer would be positive. Next, I have negative 855 raised to the 5th power. It's enclosed inside of a set of parentheses, so I look at my exponent. My exponent is a 5. 5 is an odd number, so this would be negative. Okay, now let's take a look at negative 75 to the 6th power. But notice how you don't have parentheses around negative 75. So that tells me that the result will be negative. Because I basically have the negative of 75 to the 6th power, or the opposite of 75 to the 6th power. So I would do 75 to the 6th power first, and then when I'm done, I would change the sign, which would make it negative. All right, what about negative 104 raised to the 19th power? Well, again, there's no parentheses around negative 104, so the result is going to be negative. And for our last problem, we have negative 212 raised to the 22nd power. So because this is enclosed inside of a set of parentheses, I look at my exponent and I say, is it odd? Is it even? 22 is an even number. It's divisible by 2. 22 divided by 2 is 11 with no remainder. So because of that fact, this will be positive. I would get an even number of negative factors, which gives me a positive result. Hello and welcome to Pre-Algebra Test Section 1 on exponents with an integer base. Okay, so for our problems, we just want to evaluate each. We're going to start out by looking at negative 2 raised to the 8th power. We have to pay close attention when we're working with exponents and we have a negative base. In this case, we can see that we have parentheses around the negative 2. So when this occurs, I'm essentially going to have negative 2 times 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 negative 2. 8 factors of negative 2. Now, we know that if I have an even number, of negative factors, the result is positive. Then I could just go through and multiply absolute values. So 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, 16 times 2 is 32, 32 times 2 is 64, 64 times 2 is 128, and then 128 times 2 is 256. But an easier way to look at this, if you have parentheses around your base, then the negative and the 2 are raised to this exponent, which is 8. 8 is an even number. So again, we know we'd have a positive result because I'd have an even number of negative factors. Then I could just think about what is 2 to the 8th power, and we found that was 256. So this is, again, positive 256. What about negative 2 cubed? Well, notice again how I have parentheses around my base, so the negative and the 2 are both raised to the 3rd power. But because this exponent is a 3, I'm going to get a negative result. And the reason for that is I would have an odd number of negative factors, right? I'd have negative 2 times negative 2 times negative 2. So I would get a negative result. Now I can just think about what is 2 cubed, right? What is 2 times 2 times 2? 2 times 2 is 4, 4 times 2 is 8. So this would be negative 8 as my answer. Now let's take a look at negative 2 to the 8th power. And you might say, we already did this problem. No, we didn't. I want you to pay close attention to the fact that we don't have parentheses around negative 2. So essentially what this is telling you is that I have negative 1 times 2 to the 8th power, or the opposite of 2 to the 8th power. We found earlier that 2 to the 8th power was 256. This is negative 1 times 256, which is equal to negative 256. Have to pay close attention to whether or not you have parentheses around that base. If we had negative 2 to the 8th power like this, again, we solved this earlier, we know we would get 8 factors of negative 2. An even number of negative factors gives us a positive result. So this would be positive 256. The difference is having parentheses around the base tells us that the negative and the 2 are raised to that power of 8. When we don't have it, it's just the opposite of 2 to the 8th power. What about negative 2 cubed? And notice how, again, there's no parentheses around the negative 2. So again, this is just the opposite of 2 cubed. You just think about it as negative 1 times 2 cubed. 2 cubed is 8. You just multiply negative 1 times 8, and you get negative 8. And you might stop and say, okay, well, we did negative 2 cubed earlier like this, and we got negative 8 as well. Yeah, that's true. In this case, you'd have negative 2 times negative 2 times negative 2. But just notice that the reason it's negative is not the same here. This is negative because we have an odd number of negative factors. This is negative because I'm saying, hey, I want the opposite of 2 cubed, or basically what is negative 1 times 2 cubed. So they're negative for different reasons. Okay, for the last one, we have negative 2 to the 4th power. Now again, notice how this negative 2 is enclosed inside of a set of parentheses. So in this case, the negative and the 2 are raised to the 4th power. Now thinking about this exponent here, it's a 4. 4 is an even number. So I would have an even number of negative factors, so my result would be positive. Right? So now I just think about what is 2 to the 4th power. 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. So my answer would be positive 16. Hello and welcome to Pre-Algebra Test Section 2 on exponents with an integer base. Okay, so we want to evaluate each. We start out with negative 10 to the 2nd power, otherwise known as negative 10 squared. Now I want you to notice something. We don't have any parentheses around negative 10. So when you work with exponents and your base is negative, you have to pay attention to this. If there's no parentheses around the base, then you're basically saying that you want the opposite of 10 squared. So to make that clear, I'm going to write negative 1 times 10 squared. Because of the order of operations, I would say, what is 10 squared first? 10 squared is 100. So I would say, what is negative 1 times 100? And that is negative 100. Now, if I come to this problem here, negative 10 squared, where there's parentheses around the negative 10, now what I'm saying is, hey, what is negative 10 times negative 10? The negative and the 10 are both raised to the 2nd power. So in this case, I have a negative times a negative, and that's a positive. right? An even number of negative factors gives you a positive result. And then I just think about what's 10 times 10, and that's 100. So in this case, we have positive 100. And again, in this case up here, we have negative 100 because I essentially said, hey, what's the opposite of 10 squared? All right, next we're going to look at negative 10 cubed. But again, no parentheses around the base. So if there's no parentheses around the base, it's going to be negative. Because you're saying, what is the opposite of 10 cubed? Now, 10 cubed, you can think of as a 1 followed by 3 zeros. 1, 2, 3. So we end up with negative 1,000 as our answer. What is negative 10 to the 5th power? Again, no parentheses around the base. So if there's no parentheses around the base, it's going to be negative. And then 10 to the 5th power is a 1 followed by 5 zeros. 1, 2, 3, 4, 5. So that's negative 100,000. All right, for the last problem, we have negative 10 cubed again, but now we have parentheses around our base. So what's different here is instead of me saying, in this scenario, I had the opposite of 10 cubed. And so essentially I had negative 1 times 10 cubed is 1,000. So this equals negative 1,000. Here I'm saying I want negative 10 times negative 10 times negative 10. Now this is going to be negative as well, but it's just negative for a different reason. It's negative because we have 3 negative factors. So 3 negative factors, 3 is an odd number, you get a negative result. 10 times 10 times 10 is 1,000, as we already know. So we get negative 1,000 as well. Hello and welcome to Pre-Algebra Test Section 3 on exponents with an integer base. Okay, so we just want to evaluate each. And we're looking at negative 5 squared to start. And basically what I taught you in the lesson is that you need to pay close attention to whether or not you have parentheses around your base if it's negative. So in this case, we do. We have parentheses around negative 5. And so this problem translates into negative 5 times negative 5. Right? Negative times negative is positive. And 5 times 5 is 25. Or you could also say, okay, I have an even number of negatives here, so I know the answer is positive. Again, 5 times 5 is 25. This answer is going to be different than when we work the problem this way. Now I have negative 5 squared, but notice how I don't have parentheses around negative 5. So what this is telling me is that I have the opposite of, or the negative of, 5 squared. I could write this as negative 1 times 5 squared. Now, because of the order of operations, I would do 5 squared first. 5 squared is 25, so I would have negative 1 times 25. This is basically saying I want the negative of 25, or the opposite of 25, which is negative 25. So you have to pay close attention to whether or not you have parentheses around your base, particularly when your exponent is even. Because in this scenario up here, we've got parentheses around the base, the exponent is even, so I had an even number of negative factors. That gave me a positive result. Here, I have no parentheses around the base. I have an even exponent, but because I don't have parentheses around the base, I'm asking for what is the opposite of 5 squared, and that's why I got a negative 25. Okay, here we have negative 5 cubed, and we have parentheses around our base. Now, in this case, I'm going to get a negative. And the reason is, although this is negative 5 times negative 5 times negative 5, I have 3 negative factors. 3 is an odd number, so that tells me I'm going to have a negative result. Now we just think about 5 times 5 times 5. 5 times 5 is 25. 25 times 5 is 125. So this is negative 125. Now down here I have negative 5 cubed also, but I didn't write any parentheses around negative 5. So essentially this is telling me I have the opposite of five cubed. Right, so I'm going to write that as negative 1 times 5 cubed. 5 cubed is 125, so this would be negative 1 times 125, which is negative 125. It's the same answer either way, but we arrive at it differently. Here I have the opposite of 5 cubed, which is the opposite of 125, or negative 125. Here I had 3 factors of negative 5, which again, 3 is an odd number, so that's negative, and then 3 factors of 5 is 125, so I get negative 125. Okay, so now in this scenario, we have negative 5 to the 4th power, and we have parentheses around negative 5. Now, I'm basically saying negative 5 times negative 5 times negative 5 times negative 5, right? The negative and the 5 are raised to the 4th power. So I'm looking at the exponent, and it's even. So my answer is positive, and I just think about what is 5 to the 4th power. 5 times 5 is 25, 25 times 5 is 125, 125 times 5 is 625. So this is positive 625. Now, when we get to this right here, this negative 5 to the 4th power, we notice that we get a negative. The exponent is even, but this is basically saying I want the opposite of 5 to the 4th power. The opposite of. And again, that's a notational thing because we don't have parentheses around the negative and the 5, right? So this is saying, hey, I want negative 1 times the result of 5 to the 4th power. 5 to the 4th power is 625. So you end up with negative 625 as your answer. Hello and welcome to Pre-Algebra Test Section 4 on exponents with an integer base. Okay, so for the problems we're going to look at, we're just going to determine the sign only. We don't need to answer it. So we're going to start out with negative 2 to the 15th power. And we're looking at the fact that we do have parentheses around the base. But we have a 15 for our exponent. 15 is an odd number. So I would have an odd number of negative factors. That would give me a negative result. So my sign would be negative. Next, we look at negative 8 to the 12th power. The negative 8 is inside of a set of parentheses. So I would have 12 factors of negative 8. Now 12 is an even number. An even number of negative factors gives me a positive result. What about negative 3 to the 4th power? Well, notice how there's no parentheses around negative 3. So essentially what this is saying is that I have the opposite of 3 to the 4th power. So I would do 3 to the 4th power first. That would be positive. And then I'd take the negative of that, or I'd take the opposite of that, and it would become negative. Again, if you don't have parentheses around the base and it's negative, the result is always negative. Here we have negative 7 cubed and no parentheses around the base. And as I just said, when this occurs, the result is always negative. You'd have 7 cubed done first, then you would take the opposite of that and it would become negative. All right, we have negative 1053 to the 4th power. So we do have parentheses around the base here, and our exponent is even. So that tells me that we're going to have an even number of negative factors. That would give me a positive result. All right, for the last one, we have negative 264 raised to the 13th power. Parentheses around the base here, so we're looking at our exponent. Our exponent is odd, so an odd number of negative factors gives me a negative result. Hello and welcome to Pre-Algebra Test Section 5 on exponents with an integer base. Okay, so for these problems, we're just going to determine the sign only. So we're going to start out with negative 7 to the 10th power. So notice how we have parentheses around negative 7. So that tells me I'm going to have 10 factors of negative 7. 10 is an even number. An even number of negatives gives me a positive result. Next, I have negative 4 to the 5th power. Now, although this is inside of a set of parentheses, it's still going to be negative. And the reason is because I have 5 factors of negative 4. 5 is an odd number. An odd number of negative factors is going to give me a negative result. What about negative 8 to the 19th power? Well, negative 8 is inside of a set of parentheses here, but it's raised to an odd number, right? An odd number of negative factors gives me a negative result. Next, we have negative 12 to the power of 51. Now, you might look at this and say, okay, well, this is odd, and so it's negative. But really, we don't have parentheses around the base. So when we don't have parentheses around the base, this is going to be negative. Right? Because I'm basically saying the opposite of 12 to the power of 51. Next, we have negative 1027 raised to the 16th power. So again, although this is even, we don't have parentheses around the base. So what's happening is I'm saying I want the opposite of 1027 raised to the 16th power. So this part would be positive, the 1027 raised to the 16th power. But then this, we'd say, well, what is the opposite of that? That would make it negative. Now we have negative 815 raised to the 97th power. Now we have parentheses around our base, but this number here, our exponent, is odd, so we get a negative result. Now we have negative 10,577 raised to the power of 113. And again, we have parentheses around our base, but this number right here, our exponent, is odd, so our answer is negative. For our final problem, we have negative 155,375 raised to the power of 17. Now, no parentheses around the base, so we know it's negative. Hello and welcome to Pre-Algebra Practice Set number 23. And in this video, we're going to look at some additional practice problems for our lesson on the order of operations with integers. Okay, so for the problems we're going to look at, we just want to evaluate each. And we're going to start out with this. We have inside of parentheses 48 times 2 minus a negative 12. Then we're dividing by 9. Then we're subtracting away. Inside of parentheses, we have 8 plus, and then inside of absolute value bars, negative 17 minus 6. So if we look at this problem, we have parentheses here, and we have parentheses here. And it doesn't really matter which one you start inside of first. As long as you completely take care of this one, and you completely take care of this one, before you start doing any of the operations that are outside of the parentheses, you are fine. So let's start with the parentheses here. Now, if I look, it looks like I have parentheses again right here, but again, this is just used to separate the minus a negative so that we don't have two operator symbols next to each other. So what I'm looking at is multiplication and subtraction. So I want to multiply before I subtract. So what is 48 times 2? 48 times 2. 2 times 8 is 16. 2 times 4 is 8, plus 1 is 9. So that would be 96. All right, so I'm going to replace that. We'll have inside of parentheses 96 minus a negative 12. I can go ahead and write that as plus 12, right? Minus a negative is plus a positive. And then we'll have divided by, we have this 9 minus, and then inside of parentheses we have 8 plus, and then inside of absolute value bars, negative 17 minus 6. Okay. So continuing inside of here, I just have addition. 96 plus 12. 96 plus 12. 6 plus 2 is 8. 9 plus 1 is 10. So that's 108. So I'll replace this with 108. And then I have divided by 9. And then minus. And I can go ahead and just start working inside of the parentheses here, because that would be my next step. So if I look inside the parentheses here, I have addition. And then I have some absolute value bars. Now, I always want to look for grouping symbols when I get inside of grouping symbols, right? Because I'm reapplying the order of operations. So this right here would serve as grouping symbols. We need to figure out what negative 17 minus 6 would be. Negative 17 minus 6 is the same thing as if I said, what is negative 17 plus negative 6? The answer would be negative, right? We have a common sign. And then you just do 17 plus 6, and that's 23. So this would be negative 23. So let's write this as 8 plus the absolute value of negative 23. So now continuing inside of our parentheses here, we need to figure out what the absolute value of negative 23 is first before we can add to 8, right? So the absolute value of negative 23 is 23. So we would have 108 divided by 9 minus, and then inside of parentheses we'd have 8 plus, the absolute value of negative 23 is 23. So now continuing inside of the parentheses, 8 plus 23 is 31. So we'd have 108 divided by 9 minus, again, 31. So now the problem is very, very simple. We have division and we have subtraction. So I want to divide before I subtract. So what is 108 divided by 9? So I don't know that off the top of my head. So we could quickly do a long division and figure that out. So 9 goes into 10 once. 1 times 9 is 9. Subtract here, you get 1, and bring down the 8. 9 goes into 18 twice. 2 times 9 is 18. Subtracting gets 0. So the answer for that is 12. So again, 108 divided by 9 is 12. And then we're subtracting away 31. So 12 minus 31. We can change this to 12 plus a negative 31 and use our rules for adding integers. So the first thing you would do is find the sign. The sign is going to be negative because negative 31 has a larger absolute value. Then I would subtract the smaller absolute value from the larger. So I would do 31 minus 12. Borrow here. 11 minus 2 is 9. 2 minus 1 is 1. So the answer would be negative 19. Okay, let's take a look at another one. And realistically, this should be up here. It's just, it doesn't fit on the screen, so it had to continue on the next line. And I apologize for that. But we have 3 plus, and then inside of brackets, we have this quantity 29 minus 6, then times 13. Then we're dividing by, and then inside of these parentheses, we have negative 17 minus, inside of another set of parentheses, negative 2 times 2, and then we subtract away 26. So I'm going to start inside of grouping symbols, and I have brackets here. I have parentheses here. So I'm going to start inside of these brackets, and once I get inside, I'm looking at the innermost set of grouping symbols, and that contains 29 minus 6. So 29 minus 6 is 23. So I'm going to put 3 plus, and then inside of brackets, I'm going to have 23 times 13. Then this is going to be divided by, inside of parentheses, we have negative 17 minus, and then we have inside of parentheses, negative 2 times 2, and then we're subtracting away 26. So staying inside the brackets, I have 23 times 13. So I don't know what that is off the top of my head, so let's do a vertical multiplication. 23 times 13. 3 times 3 is 9. 3 times 2 is 6. Then 1 times 23 is 23. So put the 3 here and the 2 here. Bring down the 9. 6 plus 3 is 9. Bring down the 2. So 299. So we're going to have 3 plus 299. Then we're dividing by, and then inside the parentheses here, I have a negative 17 minus. Now, once I get inside these parentheses, remember, I would go to this set of parentheses right here, and I would evaluate what is negative 2 times 2. Well, negative 2 times 2 is negative 4. Negative times positive is negative, and 2 times 2 is 4. So this would be minus a negative 4, and then we have minus 26. So continuing inside of these parentheses here, I have negative 17 minus a negative 4. That's the same thing as negative 17 plus a positive 4. So if we think about what is negative 17 plus 4, well, the sign is negative. And then I would just do 17 minus 4. 17 minus 4 is 13, so that's negative 13. So we'll have 3 plus 299 divided by, again, this is negative 13, and then minus 26. So we're done with all the grouping symbols. Now all we need to do is look at our operations involved. We have addition, division, and subtraction. And remember, although we have parentheses here, the only reason those parentheses are there is so I don't have division and then a subtraction symbol right next to each other because it looks clustered, right? So that's why we have parentheses there. All right, so now I want to divide before I do anything else. So what is 299 divided by negative 13? Well, I know it's negative, but what's 299 divided by 13? 13 goes into 29 twice. 2 times 13 is 26. Subtracting, we get 3. Bring down the 9. 13 goes into 39 exactly 3 times. 3 times 13 is 39. Subtracting gets 0. Okay, so we're going to get negative 23. So we'd have 3 plus a negative 23, and then minus a 26. So all I have now is addition and subtraction. So we work those left to right. So 3 plus negative 23 is going to be negative 20. right? Keep the sign that has the larger absolute value. In this case, that's negative 23, so the answer is negative. And then subtract the smaller absolute value, which is 3, from the larger absolute value, which would be 23. 23 minus 3 is 20, so you get negative 20. Now we're subtracting away 26. Now I can just think about this as negative 20 plus negative 26. The sign would be negative, right? Use the common sign. And then just add the absolute values. 20 plus 26 is 46. So our answer here is negative 46. Okay, for the final problem, we have this quantity, negative 12 minus 8. Then we're dividing by, we have the absolute value of negative 2 times negative 5 plus negative 6. Then we're dividing by the absolute value of 3 times negative 9 minus a negative 22. So we have grouping symbols here. The absolute value bars are going to serve as grouping symbols here and here. So what this basically tells us is, hey, figure out what this is, figure out what this is, and figure out what this is separately. Figure those results out first before you do any of the division, right? You just have to separate that. It's grouping those operations together. So I'm going to start out and just work with negative 12 minus 8 first. But it really doesn't matter. If I started with inside these absolute value bars, and then I went to this, and then I went back to that, as long as I do everything separately before I do this division, I'm okay. So negative 12 minus 8 is the same thing as negative 12 plus negative 8. That's negative 20. Okay, so now inside these absolute value bars, I have a negative 2 times a negative 5 plus a negative 6. So multiplication and addition. Now I want to multiply before I add. So negative 2 times negative 5 is going to give me positive 10. So the absolute value of 10, and then we're adding negative 6. That's basically the same thing as subtracting away 6. So I'm going to write this as 4. Because 10 plus negative 6 or 10 minus 6 is 4. So we'd have the absolute value of 4 here. Then divided by, let me write the rest of this, we have the absolute value of 3 times negative 9. Then minus a negative 22 I could just think of as plus 22. Now inside these absolute value bars I have multiplication and I have addition. So I would multiply first. What is 3 times negative 9? Positive times negative is negative. 3 times 9 is 27. So this is going to give me a negative 27. So I'd have negative 20 divided by the absolute value of 4 divided by the result of this, the absolute value of, this would be negative 27 plus 22. Now if I perform this operation, negative 27 plus 22, it's going to be negative 5. So we'll rewrite this as negative 20 divided by the absolute value of 4 divided by, and then this will be the absolute value of negative 5. So now I'm going to perform these absolute value operations. So I'm going to have negative 20 divided by the absolute value of 4 is 4, and then divided by the absolute value of negative 5 is 5. So now I just have division, and I'm going to work left to right. So negative 20 divided by 4 is negative 5. That's negative 5. And then we're dividing by 5. Negative 5 divided by 5 is negative 1. Hello and welcome to Pre-Algebra Test Section 1 on the order of operations with integers. Okay, so we want to evaluate each, and we're just looking at one problem here. So inside of brackets we have parentheses around negative 1 minus a negative 21, then times 2. Then we're dividing by this quantity, 9 plus 1. Then we're subtracting away. We have negative 15 squared. So we want to always start out by working inside of grouping symbols. So we have brackets here. We have parentheses here. And I know we have parentheses here, but this is just to enclose that negative that's being raised to the second power. So if I look inside the brackets here, I have a set of parentheses. So when we work inside of grouping symbols, we always look to reapply the order of operations. And when we do that, we look for grouping symbols again. So we start with the innermost set, and that contains negative 1 minus a negative 21. And when you do minus a negative, it's plus, you can think of this as plus a positive. So what is negative 1 plus 21? Well, that's going to be 20. you can think about that as 21 minus 1. It's just 20. So inside these brackets, I'm going to have 20 times 2. And I might as well go ahead and just do that now. 20 times 2 is 40. So let's just replace this with 40. And we can remove the brackets. So we'll just have 40 there. Now next we have divided by. We have this quantity 9 plus 1. We would do that next. What is 9 plus 1? That's 10. So then we put a 10 there. And then we have minus. And then we have this negative 15 that's being squared. Now, we have division, we have subtraction, and we have an exponent. We want to perform the exponent operation first. So what is negative 15 squared? Well, notice how you have parentheses around your base, negative 15. So that means I have two factors of negative 15, and that's positive 225. So I'll have 40 divided by, we have 10 minus, again, this is positive 225. Now I have division and subtraction. So I want to divide first. So what is 40 divided by 10? That's 4. So we'd have 4 minus 225. And we could rewrite this as 4 plus negative 225. So I know the sign is negative. And then I'm just going to subtract absolute values. Right? I do 225, which is the larger absolute value, minus 4, which is the smaller absolute value. 5 minus 4 is 1. Then bring down this 2 and this 2, and you get 221. So we drag that back up here, and our answer for this problem is negative 221. Hello, and welcome to Pre-Algebra Test Section 2 on the order of operations with integers. Okay, so we just want to evaluate each, and we only have one problem. So we have negative 24 plus 3 plus 8 minus, and then inside these brackets, it kind of got cut off. It doesn't fit on my screen, but inside the brackets, we have this quantity, negative 1 plus 13, and that's squared. And then minus, you have this quantity 2 plus 13. So let's start out. I'm just going to recopy this. Negative 24 plus 3 plus 8 minus. Now, we're going to start out inside these brackets here. And once we get inside the brackets, we have two sets of parentheses. I have one here, and I have one here. Now, it doesn't matter which one you start inside of. I can just start with negative 1 plus 13. That would be positive 12. So inside the brackets, we'd have a 12 squared. And then minus, I would still have this part right here, this 2 plus 13. I can go ahead and just take care of that. So 2 plus 13 is 15. So 15. And continuing inside the brackets there, remember, I always have to reapply my order of operations. I have this exponent, and I have subtraction. So doing the exponent is more important. So what is 12 squared? Well, I could go through and do a vertical multiplication with 12 times 12, but I already know this is 144. 2 times 2 is 4. 2 times 1 is 2. And then 1 times 12 is 12. Bring down the 4. 2 plus 2 is 4. Bring down the 1. Again, 144. So I'd have negative 24 plus 3 plus 8 minus, and then inside the brackets, I'd have 144 minus 15. So what is 144 minus 15? You can kind of use a little mental trick for this. If I had 145 minus 15, that's easy to do in your head. That's 130. But I have one less than that. So I'd end up with 129, right? Because I started out with one less than 145. So my answer should be one less, right? So I'd end up with 129. So this is negative 24 plus 3 plus 8 minus 129. Now I just have addition and subtraction, so I can work left to right. So negative 24 plus 3 is negative 21. Negative 21. Then plus 8, then minus 129. So negative 21 plus 8, we know the answer is negative, and you just do 21 minus 8. Borrow here, 11 minus 8 is 3. Bring down the 1, so that's a negative 13. And then minus 129. Now, if I'm subtracting away 129, it's the same thing as adding negative 129. So I'm going to change this to plus negative 129, like that. The sign would be negative, and then we just add 129 and 13. 9 plus 3 is 12. 1 plus 2 is 3, plus 1 is 4. Bring down the 1. So we'd end up with negative 142 as our answer. Hello and welcome to Pre-Algebra Test Section 3 on the order of operations with integers. All right, so we want to just evaluate each. So for our problem, we have inside of parentheses negative 30 times 2, then divided by, inside of brackets, we have this quantity, 28 minus 26, then times, we have another quantity here, negative 19 minus a negative 13. So we have multiple grouping symbols here. We have parentheses here, and then we have brackets here. Now it doesn't matter which one I do first. I just need to figure out the result of the parentheses here and the result of the brackets here before I tackle that division. So let's figure out what negative 30 times 2 is first. Just get that out of the way. So negative 30 times 2, negative times positive is negative. 30 times 2 is 60, so that's negative 60. So now once I look inside the brackets, I notice that I have parentheses here and here. So it doesn't matter which one I start inside of, but I need to figure out what this is and this is before I tackle that multiplication. So what is 28 minus 26? Well, that's going to be 2. So I'm going to put divided by, and then inside the brackets, I'll write this as 2 times. Next, I would think about negative 19 minus a negative 13. Minus a negative is plus a positive. So really, this is negative 19 plus 13. That's going to give me negative 6. So this will be 2 times a negative 6. So now I would just perform the operation inside the brackets. 2 times negative 6 is negative 12. So we'd have negative 60 divided by a negative 12. And negative divided by negative is positive. And then 60 divided by 12 is 5. So my answer here is 5. Hello and welcome to Pre-Algebra Test Section 4 on the order of operations with integers. All right, so we just want to evaluate each. And we're only looking at one problem here. So we have inside of brackets, this quantity negative 18 plus 9, then times 3. Then we're dividing by, inside of parentheses, we have negative 10 minus 22 plus 18 plus the absolute value of negative 5. All right, so it doesn't matter if we start inside of these brackets or these parentheses. As long as we do this and this separately before we attack this division. So let's start out with the operations inside of the brackets up top. And we would start inside the parentheses because whenever you get inside of grouping symbols, you always look for grouping symbols again, right? You're reapplying the order of operations. So we have some parentheses here with a negative 18 plus 9. Negative 18 plus 9 is negative 9. And then I would multiply by 3 after that. So negative 9 times a positive 3 is a negative 27. So the result of the brackets would be negative 27. Now I'm dividing by, and then inside the parentheses I have negative 10 minus 22 plus 18 plus the absolute value of negative 5. Now, if I look inside the parentheses here, I have subtraction, addition, addition, and then I have this absolute value operation. Now I need to do the absolute value operation first because I can't add it to something if I don't know what it is, right? So I have to figure out what is the absolute value of negative 5, and that's 5. So let's rewrite this as negative 27 divided by, and inside of parentheses we have negative 10 minus 22 plus 18, and then plus 5. Now we can add and subtract moving left to right. So I'll have negative 27 divided by, then inside the parentheses, we'll have negative 10 minus 22. So that's the same as negative 10 plus negative 22. So we know that's negative, and then 10 plus 22 is 32. So negative 32, then plus 18, then plus 5. Now, remember, addition is commutative. So what that means is that I can change the order around as much as I want. If I just have addition present, I could do 18 plus 5 first, because those two numbers are positive. So I'm going to just reorder this to 18 plus 5 plus negative 32. And I'm going to do 18 plus 5 first, again, because they're positive numbers, and that would give me 23. So I'd have negative 27 divided by, inside of parentheses I have 23, and then plus a negative 32. Okay, so now we want to do 23 plus negative 32. So we know the sign is going to be negative because negative 32 has the larger absolute value. Then what I'm going to do is I'm going to subtract 32 minus 23, and that's going to give me 9. Right? I would borrow here. 12 minus 3 is 9. So we have one final operation to perform. We have negative 27 divided by negative 9. Negative divided by negative is positive. 27 divided by 9 is 3. So we end up with 3 as our answer. Hello and welcome to Pre-Algebra Test Section 5 on the order of operations with integers. Okay, so we just want to evaluate each. And we're just looking at one problem here. Inside of brackets, we have negative 23 minus, and then inside of parentheses, we have 8 plus negative 12 times 2 minus 1 minus 12. And then we're dividing by, we have this quantity here, negative 21 minus a negative 20. So we have multiple grouping symbols involved. We have these brackets here, and we have these parentheses here. So it doesn't matter which one I start inside of, as long as I do them separately before I perform this division. I'm okay. So if I start inside the brackets, I look for the innermost set of parentheses. So that occurs right here. Okay? And I know you see parentheses around negative 12. Again, that's just so that we don't have a plus and then a minus next to each other without some separation. That's all those parentheses are for. Now, if I start inside the parentheses here, I have addition, multiplication, subtraction, and subtraction. I want to multiply first. So what is negative 12 times 2? That's negative 24. So this right here would be negative 24. And then I would just add and subtract moving left to right. So I'd have 8 plus negative 24. That would be negative 16. And then I would subtract away 1. That would be negative 17. That's like adding negative 1. And then I would subtract away 12. So I'd have negative 17 plus negative 12. So just think about the answer would be negative, and then 17 plus 12 is 29. So now that we know that the result of what's inside the parentheses here is negative 29, I can just write inside of brackets negative 23. I'd have minus a negative 29, which is plus 29. And then we're dividing by, inside the parentheses here, I'd have negative 21 minus a negative 20, we can write as plus 20. Remember, minus a negative is plus a positive. So now, inside the brackets, negative 23 plus 29 is positive 6. So I'd have 6 divided by, inside the parentheses here, negative 21 plus 20 is negative 1. So divided by negative 1. And just do this division. If you multiply or you divide by negative 1, you just change the sign of the number. So starting with 6, it's positive. If I divide by a negative 1, it becomes negative. So it's just negative 6. Hello and welcome to Pre-Algebra Practice Set number 24. And in this video, we're going to look at some additional practice problems for our lesson on divisibility rules. So we're going to start out by looking at divisibility by 2, 3, and 4. So we want to determine if each number is divisible by 2, 3, or 4. Now let me just briefly talk about the rules real quick. So if a number is divisible by 2, it's an even number, meaning its final digit is a 0, a 2, a 4, a 6, or an 8. If a number is divisible by 3, the sum of its digits, in other words, you will add the digits in the number, that number that it forms will be divisible by 3. A number will be divisible by 4. First off, it needs to be an even number, so it needs to be divisible by 2. And secondly, the final 2 digits of the number needs to form a number that's divisible by 4. So let's take a look at 162. And we're going to look at, again, 2, 3, and 4. So is it divisible by 2? Well, yes, the final digit of this number is a 2. So it's an even number. So this is a yes. Is it divisible by 3? Well, to find that out, I just sum the digits. So I'd say, what is 1 plus 6? That's 7. Then 7 plus 2 would be 9. 9 divided by 3 is 3 with no remainder. So this is a yes as well. This is also a yes. All right, what about 4? Well, again, if the number's already even, then I would look at the final two digits of the number and say, would 62 be divisible by 4? So I don't know that off the top of my head, so I could use a little quick long division. 4 goes into 6 once. 1 times 4 is 4. 6 minus 4 is 2. Bring down the 2. Does 4 go into 22? Well, yes, it does. It goes in 5 times, but there's going to be a remainder here. 5 times 4 is 20. Subtract, you get 2. So 62 is not divisible by 4, because 62 divided by 4 is 15 with a remainder of 2. So this is a no. This is a no. What about 188? And again, we're looking at 2, 3, and 4. So for 2, that one's easy. Look at the final digit of the number. That's an 8, so it's an even number. So the answer here is yes. What about 3? Again, we're going to sum the digits. So 1 plus 8 is 9. 9 plus 8 is 17. Now, some of you might not know if 17 is divisible by 3. So you can take that number 17 and you can add the digits again. What is 1 plus 7? Well, that's going to give me 8. And most of you know that 8 is not divisible by 3. 8 divided by 3 is 2 with a remainder of 2. So this is going to be a no. Then what about 4? Well, again, if it's even, then I would look at the final two digits of the number and say, is 88 divisible by 4? Is 88 divisible by 4? 4 goes into 8 twice. 2 times 4 is 8. Subtract, you get 0. Bring down the 8. 4 goes into 8 twice. 2 times 4 is 8. So yes, it is, right? 88 divided by 4 is exactly 22. There's no remainder. So this is a yes as well. All right, let's look at 4,743. So we have 2, 3, and 4. So if I look at the final digit of this number, it's a 3. That tells me that 4,743 is odd. So I can automatically say that this is no, and this is no. I don't need to do anything else for 2 or 4. If the number's not even, it's not going to be divisible by 2. It's not going to be divisible by 4. So the only thing left is 3. So we would add the digits here. 4 plus 7 is 11. 11 plus 4 is 15. 15 plus 3 is 18. 18 is divisible by 3. 18 divided by 3 is 6 with no remainder. So this would be a yes. All right, now we're going to look at 5, 6, and 8. So determine whether each number is divisible by 5, 6, or 8. So for 5, the rule is easy. If the final digit of the number is a 0 or a 5, the number is divisible by 5. So in this case, the final digit of the number is a 5. So this is a yes. Okay, for 6, we want to know, is the number divisible by both 2 and 3? So I don't even need to see if it's divisible by 3 because I know that it's not divisible by 2. If the number is odd, like it is in this case, it ends in a 5, then the number is not going to be divisible by 2, and therefore it can't be divisible by 6. The same thing is going to go for 8. You can't have a number that's odd be divisible by 8. A number that's divisible by 8 is going to have to be even. So this is going to be a no as well. Okay, what about 42,480? So again, we're looking at, let me just kind of change colors. We're looking at 5, 6, and 8. So again, for 5, does it end in a 0 or a 5? Well, yes, it does. It ends in a 0. So this is a yes. For 6, it needs to be divisible by both 2 and 3. The number ends in a 0, which means it's even, so it is divisible by 2. Is it divisible by 3? 4 plus 2 is 6. 6 plus 4 is 10. 10 plus 8 is 18. 18 divided by 3 is 6, no remainder. So 42,480 is divisible by 2 and also divisible by 3. So yes, it's going to be divisible by 6. Now, for divisibility by 8, it needs to be even, which in this case it is. And then we would check the last 3 digits of the number. So if the last 3 digits of the number form a number that's divisible by 8, the entire number is divisible by 8. So I would ask, is 480 divisible by 8? So we can go through and do a quick long division. 8 goes into 48 6 times. 6 times 8 is 48. Subtracting, you get 0. Bring down a 0. And you're basically saying, what is 0 divided by 8? That's 0. 0 times 8 is 0. Subtracting, you get 0. So 480 divided by 8 is exactly 60, right? There's no remainder. So this is going to be a yes as well. All right, now we look at 18,490. So again, we're dealing with 5, 6, and 8. So the number is divisible by 5 if it ends in a 0 or a 5. So we've got a 0 here, so that's going to be a yes. A number is divisible by 6 if it's divisible by 2, which in this case it ends in a 0, it's an even number, so that's a yes. And also 3. So for 3, we're going to sum the digits. 1 plus 8 is 9. 9 plus 4 is 13. 13 plus 9 is going to be 22. 22 is not divisible by 3. But if you didn't know that, what you can do is you can take the number you formed 22 and you just add the digits again. 2 plus 2, that's 4. You could just say, okay, well, is 4 divisible by 3? 4 divided by 3 will give you a remainder, right? It's 1 with a remainder of 1. So the answer is no. This number is not divisible by 3, and so it can't be divisible by 6. So this is a no. So lastly, we'd look at 8. So if the number's even, you look at the final 3 digits of the number. So in this case, it's 490. You could say, is that divisible by 8? Now, in the last problem, we dealt with 480, right? And we said 480 divided by 8 was 60. I want you to think about something for a second. Remember the trick for trailing zeros. If I did 6 times 8, that'd be 48. So if I did 60 times 8, that'd be 480. Okay, so if we know that 60 times 8 is 480, 61 times 8 would be 8 more than that, or 488. So I know that 490 is not going to be divisible by 8, right? Because 62 times 8 would be too big. It would pass this up. 61 times 8 is too small. So there will be a remainder if we divide 490 by 8. So we can go ahead and just stop there and say no. All right, now we want to determine whether each number is divisible by 9, 10, or 12. 9, 10, or 12. So 9, 10, 12. All right, so the rule for 9 is similar to the rule for 3. You sum the digits. If that result is divisible by 9, then your number is divisible by 9. So for 93,328, we make a sum here. 9 plus 3 is 12. 12 plus 3 is 15. 15 plus 2 is 17. 17 plus 8 is 25. Now, most of you will know that 25 is not divisible by 9. But if you get that result and you're unsure, you can go through and just add the digits of the new number that you just got. So 2 plus 5 is 7. 7 is definitely not divisible by 9. So this is a big fat no. This is a no. What about 10? For a number to be divisible by 10, the final digit has to be a 0. Our final digit is an 8, so this is a no as well. What about 12? For a number to be divisible by 12, it needs to be divisible by 3, and it needs to be divisible by 4. Now, if I look at the final 2 digits of this number, 28 is divisible by 4. 28 divided by 4 is 7. So I need to check and see if it's divisible by 3. So again, 9 plus 3 is 12. 12 plus 3 is 15. 15 plus 2 is 17. 17 plus 8 is 25. 25 is not divisible by 3. And again, if you want to, you can add 2 plus 5, the digits in the 25, to get 7 and say, okay, is 7 divisible by 3? No, it's not. So we would put a no here. It's not divisible by 12 because it's not divisible by 3. What about 38,979? Again, we're looking at 9, 10, and 12. So for 9, we sum the digits. 3 plus 8 is 11. 11 plus 9 is 20. 20 plus 7 is 27. 27 plus 9 is 36. 36 is divisible by 9. 36 divided by 9 is 4, no remainder. So this one is going to be a yes. What about 10? Number is divisible by 10 if the final digit is a 0. So this one's going to be a no. And then what about 12? If a number is divisible by 9, it's automatically divisible by 3. So we're covered there. But this number is an odd number. If you have an odd number, it's not going to be divisible by 4. So it fails the divisibility by 4. So no, it's not going to be divisible by 12. Again, for divisibility by 12, it has to be divisible by both 4 and 3. What about 18,360? Well, again, we're looking at 9, 10, and 12. So for 9, we sum the digits. 1 plus 8 is 9, 9 plus 3 is 12, 12 plus 6 is 18, 18 plus 0 is still 18. 18 divided by 9 is 2 with no remainder. Or you could say, okay, 18, add those digits, 1 plus 8 is 9, 9 divided by 9 is 1, no remainder. You can keep adding until you get to a number that you recognize whether or not it's divisible by 9 or not. But yes, it is going to be divisible by 9. What about 10? Number is divisible by 10 if the final digit is a 0. So this one's going to be a yes also. What about 12? A number is divisible by 12 if it's divisible by both 4 and 3. So we know it's divisible by 3. If a number is divisible by 9, it's automatically divisible by 3. Is it divisible by 4? Well, it's even, and the final two digits would make the number 60. 60 divided by 4 is 15, no remainder. So this is yes. So now we're going to look at 7 and 11. And basically this is one of the kind of harder situations that you come across because you have to go through a step-by-step procedure to see if you have divisibility by these two numbers. In fact, a lot of teachers just skip these two numbers over. So determine whether each number is divisible by 7 or 11. So I have 3,192. So divisibility by 7. Let's start with that. Now, the procedure goes as follows. You're going to cut off the final digit of the number. So in this case, it's a 2. I'm just going to chop that off, and I'm going to have the number 319 now. I'm going to take this number that I chopped off, and I'm going to double it. So 2 times 2 is 4. When I double a number, I multiply it by 2. 2 times 2 is 4, and then I subtract it away from this shortened number. So 319 minus 4 is 315. So if the number formed is a 0, or it's a number that's divisible by 7, we know that the original number is divisible by 7. Now, in this case, I have 315. I don't know if that's divisible by 7 or not, so I keep going. I know it's not a 0. So I just repeat the process again. So let me erase this, and we're just kind of starting with 315. So you would cut off the final digit, okay, and so you just have the number 31. So you have 31, you multiply the digit that you cut off by 2, 5 times 2 is 10, and you subtract it away. So 31 minus 10 is 21. Now, I know that 21 is divisible by 7. I know that from watching football, right? 3 touchdowns with extra points, 21 points. So 21 divided by 7 is 3. No remainder. So then I can stop here and say, yes, this number is divisible by 7. Yes. Now what about 11? The rule for 11 is a little peculiar also. So what I'm going to do is I'm going to number the digits. So for 11, I'm going to number the digits. Let me see here. Get a little room going. I got 3,192. So this is digit 1, this is 2, this is 3, this is 4. So what I'm going to do is sum the digits that are in the odd places, meaning the digits that's in position 1 and 3. So 3 plus 9. And then I'm going to subtract away the sum of the digits in the even places. So 1 plus 2. 1 plus 2. Now, if the result here is either a 0 or divisible by 11, you know your original number is divisible by 11. So 3 plus 9 is 12. Then we're subtracting away 1 plus 2, that's 3. So 12 minus 3 is 9. 9 is not divisible by 11. So this is a big fat no. No. Let's take a look at one more. We're looking at 7 and 11. So for 7, this might take a little time. So this is one of those ones that's just very tedious. Again, we're going to cut off the final digit of this number, 3,252,480. So 325,248. And I'm going to take this final digit that I cut off, multiply it by 2, but 0 times 2 is 0. And then I would subtract it away, but if I subtract away 0, I have the same number. So I don't know if this is divisible by 7, I just keep going. So I'm going to cut off this 8, and I'm going to have 32524. So 32,524. I'm going to double that number that I cut off. So 8 times 2 is 16, and I'm going to subtract it away. Let me scroll down here. 14 minus 6 is 8. 1 minus 1 is 0. Everything else can just come down. So I have no idea if this is divisible by 7 yet, so I keep going. Cut off this digit, and I'm going to have 3250. I'll double 8, that's going to give me 16, and subtract it away. So borrow here. 10 minus 6 is 4, 4 minus 1 is 3. Bring this down, bring this down. Continue. I'm going to cut this off. I'm going to have 323, and I'm going to double 4, that's 8, and I'm going to subtract it away. So borrow here. 13 minus 8 is 5. Bring down the 1, bring down the 3. Cut this off. So now I'm going to have 31. I'm going to double 5. That's going to give me 10, and I'm going to subtract it away. So I'm going to get 21. And again, I know that that's divisible by 7 because of watching football. I know that's 3 touchdowns. 7 times 3 is 21. So I can go all the way back up here and say that this is a big fat yes. What about 11? So I'm going to take my number, and I'm going to number it. I start out at the very left, and I'm going to say that that is 1. Then this is 2, then 3, then 4, then 5, then 6, then 7. So what I'm going to do is I'm going to sum the numbers that are in the odd places. So the numbers that are in the first position, the third position, the fifth position, the seventh position. So 3, which again is in the first position, plus 5, which again is in the third position, plus 4, which is in the fifth position, plus 0, which is in the seventh position. Then I am subtracting away the sum of the numbers in the even places. So in the second position, I have a 2. Then plus in the fourth position, I have a 2. Then plus in the sixth position, I have an 8. Now, if the result is a 0 or something divisible by 11, my original number is divisible by 11. So 3 plus 5 is 8. 8 plus 4 is 12. 12 plus 0 is still 12. Subtracting away, 2 plus 2 is 4. 4 plus 8 is 12. So 12 minus 12 is 0. So yes, if I get, again, a 0 or something divisible by 11, my original number is divisible by 11. Here I got a 0. So I'm going to put a big fat yes next to 11. Hello and welcome to Pre-Algebra Test Section 1 on divisibility rules. All right, so we want to determine if each number is divisible by 2, 3, 4, 5, or 6. So we're going to start out with 58,738. So let's write out the numbers we're trying to find if this number is divisible by. Again, we have 2, 3, 4, 5, or 6. Now, if you didn't watch the lesson, I would advise you to go back and watch it, at least so you can write down the rules that I gave you. If not, you can write them down here. A number is divisible by 2 if the final digit is a 0, a 2, a 4, a 6, or an 8, meaning it's an even number. Now, this number ends in an 8, so it is even, and so it is divisible by 2. So this is a yes. A number is divisible by 3 if the sum of its digits forms a number that's divisible by 3. So I would go through and sum the digits here. So 5 plus 8 is 13. 13 plus 7 is 20. 20 plus 3 is 23. And then 23 plus 8 is 31. Now 31 is not divisible by 3. But one of the things you can do if you add the digits and you get 31 and you say, well, I don't know if that's divisible by 3. You can add the digits again. So I can take 31 and do, okay, what's 3 plus 1? That's 4. And most of you will now know that 4 is definitely not divisible by 3. So this number is not divisible by 3. So this is a big fat no. All right, what about divisibility by 4? Well, the first thing is a number is divisible by 4 if it's divisible by 2, okay, so it has to be an even number, and then also the final 2 digits of the number have to form a number that's divisible by 4. So if you look at 38, and we were to say 38 divided by 4 equals what? Would that result give us a remainder or not? Well, these numbers are small enough to where we could work backwards. What times 4 would equal 38? Well, I know that 9 times 4 is 36. That's too small. And 10 times 4 is 40. That's too big. So unfortunately, this would produce a remainder, 38 divided by 4. So because 38 is not divisible by 4, this number 58,738 is not divisible by 4. So this is going to be a no. This is a no. Next, we look at divisibility by 5. So a number is divisible by 5 if it ends in a 0 or a 5. This number ends in an 8, so the answer is going to be no. And then for 6, a number is divisible by 6 if it's divisible by both 2 and 3. Has to be divisible by both. So I can just look back here and say, yes, it's divisible by 2, but no, it's not divisible by 3. So because it's not divisible by 3, it's not going to be divisible by 6. All right, look at 24,665. So again, we're looking at 2, 3, 4, 5, and 6. So is this number divisible by 2? Well, the answer here is no, right? This number is odd. It ends in a 5. So again, a number has to be even to be divisible by 2, meaning it has to end in a 0, a 2, a 4, a 6, or an 8. This ends in 5, so it's an odd number, and this is going to be a no. Now, I can answer a lot of questions based on that no. I can answer 4 with a no, and I can answer 6 with a no. If a number is not even, it's not going to be divisible by 4. It has to be divisible by 2 to be divisible by 4. If a number is not divisible by 2, it can't be divisible by 6. For a number to be divisible by 6, it has to be divisible by both 2 and 3. So those are all no's. Let's check 3 and 5. So for 3, I sum the digits. So 2 plus 4 is 6, 6 plus 6 is 12, 12 plus 6 is 18, 18 plus 5 is 23. Now that's not divisible by 3. And again, if you get to the conclusion of 23 and you go, well, I don't know if that's divisible by 3 or not, you can add the digits again. 2 plus 3 would give you 5. 5 is definitely not divisible by 3. Right? You can keep adding until you get the simple one-digit number. So this would be a no also. Now what about 5? Is this divisible by 5? Well, yes, it is. A number is divisible by 5 if the final digit is a 0 or a 5. So the final digit here is a 5. So this is going to be a yes. What about 79,200? So again, we're looking at 2, 3, 4, 5, and 6. All right, so we're starting out with 2. A number is divisible by 2 if it's even, and this number ends in a 0. So it is an even number, so this is going to be a yes. What about 3? Well, we'd sum the digits. 7 plus 9 is 16, 16 plus 2 is 18. So you could either stop there and say, okay, 18 divided by 3 is 6, no remainder, so it's a yes. Or you could take that 18 and you could add again. You could say 1 plus 8 is 9. 9 divided by 3 is 3, no remainder. So either way, this is a yes. What about 4? Well, we'd start out by asking, is it even, right? Is it divisible by 2? The answer is yes. And then you look at the final 2 digits of the number. In this case, we have a double 0, which is just 0. And we say, is 0 divisible by 4? Yes, it is. Don't say no. Yes, it is. 0 divided by 4 is 0 with no remainder. So it is divisible by 4. So this is a yes as well. What about 5? That's going to be a yes because the final digit of the number is a 0. And the final digit of the number, if it's a 0 or a 5, that number will be divisible by 5. Then lastly, is it divisible by 6? Well, we look at 2 and we look at 3. If a number is divisible by both 2 and 3, it is divisible by 6. So this is a yes as well. Hello and welcome to Pre-Algebra Test Section 2 on divisibility rules. All right, so we want to determine if each number is divisible by 2, 3, 4, 5, or 6. So let's start out with 21,820. So we have 2, 3, 4, 5, or 6. So we start out with 2. A number is divisible by 2 if it's even, so that means the final digit is a 0, a 2, a 4, a 6, or an 8. This final digit is a 0, so this is a yes, right? This number is even, so it is divisible by 2. For divisibility by 3, we sum the digits. So 2 plus 1 is 3, 3 plus 8 is 11, 11 plus 2 is 13. So is 13 divisible by 3? And if you don't know the answer to that and you don't want to go through and do long division, you could then take the 13, the result you got, and you could add the digits again. What's 1 plus 3? That's 4. And you could say, is 4 divisible by 3? 4 is not divisible by 3. 4 divided by 3 is 1 with a remainder of 1. So this one is a no. What about 4? Well, the first thing is it needs to be even, right? Which we know it is because it's divisible by 2. The second thing is we look at the final 2 digits of the number. If it forms a number that's divisible by 4, which in this case we'd have 20, 20 divided by 4 is 5, no remainder, then the entire number is divisible by 4. In this case, it's going to be a yes. Because again, this 20, the final 2 digits of the number, is divisible by 4. All right, for 5, we want to look at the final digit of the number. If it's a 0 or a 5, the number is divisible by 5. So here we have a 0, and so yes, this is going to be divisible by 5. For 6, we don't need to do any additional work. We've already done the work. For 6, we're looking at divisibility by both 2 and 3. Has to have both, can't just have one. So in this case, it's yes here and no here. So it's not going to be divisible by 6, right? It has to be divisible by both, and it fails for divisibility by 3. All right, let's take a look at 39,702. So we're looking at 2, 3, 4, 5, and 6. So is it divisible by 2? Yes, the final digit is a 2. This is an even number, so this is yes. Is it divisible by 3? Sum the digits. 3 plus 9 is 12. 12 plus 7 is 19. 19 plus 2 is 21. 21 is divisible by 3. 21 divided by 3 is 7. Or what you can do is take that 21, the results you got from summing the digits, and you could sum the digits again. 21 has a 2 and a 1, so 2 plus 1 is 3. Of course, 3 is divisible by 3. 3 divided by 3 is 1, no remainder. So this is a yes. What about 4? For 4, it has to be even, so that's a yes. And it has to have the final 2 digits of the number form a number that's divisible by 4. Now, if we look at it, we have 2. 2 is not large enough to split up into equal groups of 4 without going into fractions or decimals, right? Just talking about using whole numbers. So 2 divided by 4 would be 0 with a remainder of 2. So this would be a no. This is a no. Then what about 5? We're looking at the final digit of the number. If it's a 0 or a 5, the number is divisible by 5. In this case, we have a 2, right? So that's going to be a no as well. What about 6? Well, again, a number is divisible by 6 if it's divisible by both 2 and 3. So it is divisible by 2, and it is divisible by 3. So this is going to be a yes as well. Last one, we have 13,680. So again, is it divisible by 2, 3, 4, 5, and then 6? So divisibility by 2. The final digit is a 0, so this is a yes. What about 3? Well, you'd sum the digits. 1 plus 3 is 4, 4 plus 6 is 10, 10 plus 8 is 18, 18 plus 0 is still 18. And you could stop there and say, okay, well, 18 divided by 3 is 6, no remainder. Or you could sum the digits again. If you take 18 and you sum the digits, 1 plus 8 is 9. So 9 divided by 3 is 3, no remainder. Either way, it's a yes. Then what about 4? Well, it has to be even, and it is, right? It's divisible by 2. And it has to have the final 2 digits of that number form a number that's divisible by 4. I think most of us know that 80 divided by 4 is 20, right? No remainder. So this is also a yes. What about 5? For 5, the final digit must be a 0 or 5, so this is going to be a yes. And then for 6, we know it's going to be a yes because it has to be divisible by both 2 and 3, and in each case it is. So this number, 13,680, is divisible by 2, 3, 4, 5, and 6. Hello and welcome to Pre-Algebra Test Section 3 on divisibility rules. All right, so we want to determine if each number is divisible by 5, 6, 8, 9, or 10. So we're starting out with 18,608. So again, we're working with 5, 6, 8, 9, and then 10. So what's the rule for 5? Well, we look at the final digit of the number. If it's a 0 or a 5, that means the number is divisible by 5. Our final digit's an 8, so this is going to be a no. Now we move on to 6. A number is divisible by 6 if it is divisible by 2, and also divisible by 3. So I know it's divisible by 2 because the last digit is an 8, which means this is an even number. Is it divisible by 3? Well, I would sum the digits up. 1 plus 8 is 9, 9 plus 6 is 15, 15 plus 8 is 23. Now you can stop there and say, is 23 divisible by 3? Or you could add the digits in 23. 2 plus 3 is 5, and you could just say, is 5 divisible by 3? 5 is not divisible by 3. 5 divided by 3 is 1 with a remainder of 2. Because this number is not divisible by 3, it's not going to be divisible by 6. So this is a no. What about divisibility by 8? Well, for divisibility by 8, the number has to start off by being even. So that's a yes, right? The final digit's an 8. That's okay. Then we look at the final 3 digits of the number. If the final 3 digits of the number form a number that's divisible by 8, the number's divisible by 8. So I would have to go through and say, okay, 608 divided by 8 equals what? 8 goes into 60 7 times. 7 times 8 is 56. Subtract, you get 4. Bring down the 8. 8 goes into 48 6 times. 6 times 8 is 48. Subtract, you get 0. So 608 divided by 8 is 76 with no remainder. So this is going to be a yes. This is going to be a yes. What about 9? Well, I can tell you already that's going to be a no. We summed these digits already. We found that the sum was 23, and 23 is not divisible by 9. So this is going to be a no. Then lastly, we have 10. So a number is divisible by 10 if the final digit is a 0. Our final digit's an 8, so this is a no as well. What about 28,926? So again, we're working with, we have 5, 6, 8, 9, and 10. So a number is divisible by 5 if the final digit is a 0 or a 5. So this is going to be a no. A number is divisible by 6 if it's divisible by 2. In this case it is, right? The final digit is a 6, so it's an even number. And if it's also divisible by 3. So if I sum the digits here, 2 plus 8 is 10, 10 plus 9 is 19, 19 plus 2 is 21, 21 plus 6 is 27. So I can do 27 divided by 3, or I could sum the digits in 27. 2 plus 7 is 9. 9 divided by 3 is 3, no remainder. So either way, it is divisible by 3. And so because it's divisible by both 3 and 2, this is a yes. What about 8? We look at the final 3 digits of the number, and we see that it's 926. So is that divisible by 8? 8 goes into 9 once. 1 times 8 is 8. Subtract, bring down the 2. 8 goes into 12 once. 1 times 8 is 8. Subtract, bring down the 6. 8 goes into 46. We already know there's going to be a remainder here. If you think about what times 8 would give you 46, so 5 times 8 is 40. 6 times 8 is 48. That's too big. Right? So if I put a 5 here, 5 times 8 is 40. We subtract and we have a remainder of 6. So this is going to be a no. This number is not divisible by 8 because 926, the final 3 digits of the number, is not divisible by 8. So for 9, we've already summed the digits and found that it was 27. So you can say that 27 divided by 9 is 3, no remainder. Or you could keep summing the digits. So you could say, okay, I got 27, and I would sum the digits again. I get 2 plus 7, that's 9. And then try it. 9 divided by 9 is 1, no remainder. So either way, this is a yes. What about 10? For a number to be divisible by 10, the final digit should be a 0. In this case, it's a 6. So this is going to be a no. All right, last one, we have 280,800. So again, the numbers we're working with, we have 5, 6, 8, 9, and 10. So for 5, the final digit should be a 0 or 5. In this case, it's a 0, so this is a yes. For 6, the number should be divisible by both 2 and 3. So its final digit is a 0, meaning it's even, so it's divisible by 2. And the sum of the digits, you have 2 plus 8, that's 10. Plus 0 is still 10. Plus 8 is 18. Plus 0 is still 18. Now, 18 divided by 3 is 6, no remainder. Or you could take that sum that you got, 18, and you could sum the digits again. 1 plus 8 is 9. Then try it. 9 divided by 3 is 3. no remainder. So either way you do that, it's going to be a yes. What about 8? Well, again, it's got to be even, and the last 3 digits of the number, which is 800 in this case, has to be divisible by 8. Most of you will know that 800 divided by 8 is exactly 100, right? There's no remainder, so this is also a yes. What about 9? Well, we previously summed the digits here, and we found that we got 18. Again, 18 divided by 9 is 2, no remainder. Or sum the digits for 18. 1 plus 8 is 9. Then do it again. 9 divided by 9 is 1, no remainder. So this is also a yes. And then for 10, the final digit is a 0. So this is divisible by 10. So this is a yes as well. So 280,800 is divisible by 5, 6, 8, 9, and 10. Hello and welcome to Pre-Algebra Test Section 4 on divisibility rules. All right, so we want to determine if each number is divisible by 8, 9, 10, or 12. So let's take a look at 92,502. So again, we want to know if it's divisible by 8, 9, 10, or 12. So what about 8? Well, the number has to be even, which in this case it is. And then the final 3 digits of the number needs to form a number that's divisible by 8. So we look at the final 3 digits. So 502, is that divisible by 8? 8 goes into 50 6 times. 6 times 8 is 48. Subtracting, you get 2. Bring down the 2. You could stop there if you want. 8 goes into 22 twice. You're going to have a remainder. 2 times 8 is 16. Subtract. 12 minus 6 is 6. So that's your remainder. So this answer is going to be no. What about 9? For 9, you sum the digits. So 9 plus 2 is 11. 11 plus 5 is 16. 16 plus 2 is 18. So you can say, okay, is 18 divisible by 9? Or that answer that you got where you sum the digits, you could sum the digits again. The same trick will work. So 1 plus 8 would be 9. You could also say, is 9 divisible by 9? Either way, the answer is yes. 18 divided by 9 is 2, no remainder. 9 divided by 9 is 1, no remainder. So this is a yes. For 10, we look to see if the number is ending with a 0. If it's not, then it's not divisible by 10. In this case, our final digit's a 2, so this is a no. Lastly, we look at 12. So for a number to be divisible by 12, it needs to be divisible by 4 and 3. So I know that it's divisible by 3 because it's divisible by 9. But for 4, it needs to be even, which it is, and then the final 2 digits of the number, which in this case it would just be the number 2, needs to form a number that is divisible by 4. 2 is not divisible by 4. 2 divided by 4 would be 0 with a remainder of 2. So this is going to be a no. All right, next we look at 47,736. So again, we were looking at 8, 9, 10, and 12. 8, 9, 10, and 12. So for 8, again, you're looking at, is it even, which in this case it is, and what about the final 3 digits of the number, the 736? Is that divisible by 8? 8 goes into 73 9 times. 9 times 8 is 72. Subtract them and get 1. Bring down the 6. 8 goes into 16 twice. 2 times 8 is 16. Subtract and you get 0. So your answer here is going to be yes, right? Because 736 divided by 8 is exactly 92, right? There's no remainder. So this is going to be a yes. What about 9? Again, for 9, we sum the digits. So 4 plus 7 is 11. 11 plus 7 is 18. 18 plus 3 is 21. 21 plus 6 is 27. So most of you know 27 divided by 9 is 3, no remainder. If you don't, you can continue. You can take 27 and sum the digits again. 2 plus 7 is 9. And then you know that 9 is divisible by 9, right? 9 divided by 9 is 1, no remainder. So this is a yes. What about 10? That's probably the easiest one here. Just look at the final digit. If that's not a 0, then the answer is no. What about 12? For 12, it needs to be divisible by 3, which in this case, because it's divisible by 9, it's automatically divisible by 3. And it needs to be divisible by 4. So look at the final 2 digits of the number. If a number is divisible by 4, the final 2 digits of the number, which in this case it would be 36, should be divisible by 4. 36 divided by 4 is 9, no remainder. So this is a yes. Also, we could have said that if a number is divisible by 8, it's automatically divisible by 4. Either way, yes, it's going to be divisible by 12. All right, let's take a look at 181,440. So again, we're working with the numbers 8, 9, 10, and 12. So what about 8? Again, we're looking at the final 3 digits of the number. Looking at 440. Is that divisible by 8? So 440, divide that by 8. 8 goes into 44 5 times. 5 times 8 is 40. Subtract and you get 4. Bring down the 0. 8 goes into 45 times. 5 times 8 is 40. Subtract and you get 0. So this is going to be a yes. This is going to be a yes. And again, because 440 divided by 8 is 55 with no remainder. All right, what about 9? Again, sum the digits. 1 plus 8 is 9. 9 plus 1 is 10. Then plus 4 is 14. Plus another 4 is 18. Plus 0 is still 18. We know that 18 divided by 9 is 2, no remainder. Again, you could continue. You could take 18 and then sum those digits. 1 plus 8 is 9. Then use the trick. 9 divided by 9 is 1, no remainder. Either way, this is yes. What about 10? Again, look at the final digit of the number. If that's a 0, then this is a yes. In this case, we do have a 0, right? So it is divisible by 10. And then what about 12? Well, all I need to do is look at the 8 and the 9. If it's divisible by 8, it's divisible by 4. If it's divisible by 9, it's divisible by 3. For 12, we need divisibility by 4 and 3. So this is going to be a yes. Hello and welcome to Pre-Algebra Test Section 5 on divisibility rules. All right, let's look at some where we test out divisibility by 7 or 11. So determine if each number is divisible by 7 or 11. So we have 104,720. So the test for 7 is a bit time consuming. You cut off the final digit of the number. So if I cut that off, I'd have 10472. So 10,472. I then take that final digit that I cut off, I double it. So I multiply it by 2. 0 times 2 is still 0. Now, I subtract that away from this new number that I have. If I subtract away 0, I have the same number. At the end of this process, if I don't have a number that's either 0 or something that I recognize as divisible by 7, I just repeat it. So I cut off the final digit. So cut that off, I'd have 1047. Then I'm going to double this. 2 times 2 is 4, and subtract it away. So this would be 1043. So it's not 0, and I don't know if it's divisible by 7 or not yet, so I'm going to continue. So I'm going to cut off the final digit of the number. I'd have 104. Double that number. 3 times 2 is 6, and subtract. I'm going to borrow here. This will become 10, then 9, then 14. So 14 minus 6 is 8. Bring down the 9, and I have 98. At this point, you could stop because 98 is divisible by 7. 98 divided by 7 is exactly 14. But if you didn't know that, you could continue. You could cut off the 8, so you'd have a 9. Cut off the 8 and double it. So 8 times 2 is 16. So I'm saying, what is 9 minus 16? So we're involving some negative numbers here. So what is 9 minus 16? That's the same thing as 9 plus negative 16. So the larger absolute value wins. So this would be a negative. And then you do 16 minus 9, and that's 7. So ask yourself the question, is negative 7 divisible by 7? Well, the answer is yes, it is. Negative 7 divided by 7 is negative 1. There's no remainder. Let's put a 7 here and say yes. Now for 11, what we do is we number the digits. We number our digits. So we have 104,720. Start right here. Let me change colors. So start at the left. That's digit number 1. Then this is going to be 2, then 3, then 4, then 5, then 6. So you're going to take all your digits that are in an odd place, meaning the digits that's in position of 1, 3, and 5. You're going to add them together. So you'll have 1 plus 4 plus 2. And then I'm going to subtract away the sum of the digits that are in the even places. So in 2, 4, and 6. So I have a 0, plus a 7 plus another 0. So this is just 7. So when I perform this operation, I'm looking for either a 0 or a number that is divisible by 11. Either way, it will tell me it's divisible by 11. If I don't get that result, it's not. So 1 plus 4 is 5, 5 plus 2 is 7. And then minus, here I have 0 plus 7 plus 0, that's 7. So I do get a 0, so this number is divisible by 11. So this is also a yes. All right, now we're looking at 334,180. So again, to do divisibility by 7, cut off the last digit. So we'd have 33418. So 33,418. Double the digits you cut off and subtract it away. 0 times 2 is 0. Subtract it away, you get the same thing. Repeat the process. Take this away. So you get 3341. Double what you took off. So 8 times 2 is 16. Subtract it away. 11 minus 6 is 5. 3 minus 1 is 2. Bring down the 3 and the 3. So I get 3,325. So let me just erase this. 3,325. Keep going. I'm going to cut this off, and I'm going to double it. So 332 is what I have, 332. Double 5, you get 10. Subtract it away. 2 minus 0 is 2. 3 minus 1 is 2. Bring down the 3. So I get 322. And I'm going to continue. So cut this off. I'll just have 32. Double 2, you get 4. Subtract that away. So 32 minus 4 is 28. And I immediately recognize that 28 is divisible by 7. Right? From watching football, I know that if a team gets 4 touchdowns and 4 extra points, they have 28 points on the board. So 7 times 4 is 28, or 28 divided by 7 is 4. So this is going to be a big fat yes. All right, what about 11? Again, number the digits. So 11, we have 334,180. So I'll number the digits. Starting at the leftmost number, it's a 1, then 2, then 3, then 4, then 5, then 6. So the odd positions, this one, and this one, you're going to sum those numbers. So 3 plus 4 plus 8. 3 plus 4 plus 8. Subtract away the sum of the even positions. So here, here, and here. So 3 plus 1 plus 0. Now, if the result is 0 or something divisible by 11, the number is divisible by 11. 3 plus 4 is 7. 7 plus 8 is 15. Subtracting away, 3 plus 1, that's 4, plus 0 is still 4. So 15 minus 4 is 11. 11 is divisible by 11. 11 divided by 11 is 1, no remainder. So this is a big fat yes as well. Okay, let's take a look at one final problem. We have 1,049,070. So divisibility by 7. Again, cut off the final number. So you'd have 1,04907. So 104,907. Double the number you cut off. If you double 0, you have 0. Subtract it away. You subtract away 0, you have the same number. So do it again. Cut off the 7. So I'd have a 10490. So 10,490. Double 7. 7 times 2 is 14. Subtract it away. So I borrow here. 10 minus 4 is 6. 8 minus 1 is 7. Bring down the 4, the 0, and the 1. And I have 10,476. Continue. So 10,476. Cut off the final digit. So I have 1,047 now. Double that 6, you'll get 12. Subtract. 7 minus 2 is 5. 4 minus 1 is 3. Bring down the 0 and the 1. So I have 1,035. Cut off the 5. I have 103. Double it. 5 times 2 is 10. Subtract it away. 3 minus 0 is 3. 10 minus 1 is 9. So I have 93 now. So cut off the 3, and you'll just be left with 9. So I'll have a 9. Double 3, and you'll get 6. Subtract that away, and you get 3. 3 is definitely not divisible by 7. So we can stop here and say that the answer is no. All right, what about 11? So what I can do, again, number the digits in the number 1,049,070. So 1,049,070. So we're looking at odd and even. So start at the left. This is 1. This is 2. This is 3. This is 4. This is 5. This is 6. This is 7. What you're doing is you're adding all the digits that are in an odd position. So you take 1, that's in the first position. You add it to 4, that's in the third position. You add it to 0, that's in the fifth position. And you add it to 0, that's in the seventh position. All right, these are all your odd numbered positions you can think of. Again, 1 is in the first position, 4 is in the third position, 0 is in the fifth position, 0 is in the seventh position. Now I'm going to subtract away the sum of the numbers that are in the even position. So I'm just looking at kind of the opposite of just what I did. So the number that's in the second position is 0, then plus the number that's in the fourth position is 9, then plus the number that's in the sixth position is 7. Now, if the result here is either 0 or divisible by 11, the number's divisible by 11. So 1 plus 4 is 5, plus 0 is still 5. Then minus, we have 0 plus 9 plus 7. That's 16. Now, 5 minus 16 is negative 11. Now, you might go, well, we'll have some negatives involved here. That doesn't matter. Negative 11 divided by 11 is negative 1. There's no remainder. So that's the definition of divisibility. Since negative 11 divided by 11 is negative 1 with no remainder, negative 11 is divisible by 11. So this is a yes. We can go back up here and put a yes. This number will be divisible by 11. Hello and welcome to Pre-Algebra Practice Set number 25. In this video, we're going to look at some additional practice problems for our lesson on factoring whole numbers. So we begin with a basic exercise. Determine if each number is prime, composite, or neither. So remember, we think about the whole numbers, starts with 0, increases in increments of 1, out indefinitely. Now, for the definition of a prime number, you're only thinking about the whole numbers larger than 1. So you exclude 0 and 1. And that's the same for the composite number as well. So when you look at the numbers in this group, any number that is only divisible by 1 or itself is prime. Any number that is divisible by something other than 1 or itself is composite. And then the numbers that would be neither would be 0 and 1. They're excluded from the definition of prime or composite, right? Because it's any whole number larger than 1. Okay, so let's start out with the number 7. So how do we tell if this number is prime, composite, or neither? Well, it's in that group of numbers, again, starting with 2 and increasing out in increments of 1 out indefinitely. So we know it's not neither. So it's either prime or composite. So one of the two. Now, one of the ways that your book probably tells you is to look at the numbers. So if it's 7, you would look at 1 less. So you'd look at 6, you'd look at 5, 4, 3, 2, and you wouldn't look at 1 because in the definition of a prime number, it's divisible by 1 in itself. That's why we didn't look at 7. It's not an even number, so it's not divisible by 2, 4, or 6. 7 is not divisible by 3, and it's not divisible by 5, so this is a prime number. Now, a quick way to do this when we start getting into larger numbers is to take the square root of the number. And again, I talked to you in the lesson about the fact that we haven't covered square roots yet, but you can just punch up the square root of 7 on your calculator. When you do that, you're going to get about 2.64, right? Not exactly, but about. So what you do is just go to the next highest whole number. So that would be 3. So all you need to do is test the prime numbers up to and including that number, which is 3. So I would just test 2 and 3. I don't really need to test 2 because it's not an even number. I would just look and say, is 7 divisible by 3? No, it's not. 7 divided by 3 is 2 with a remainder of 1. So again, this is a prime number. What about 9? Well, I know 9 is not prime because it's divisible by 3, right? 9 divided by 3 is 3 with no remainder. So this is composite. What about 189? Well, I can use my trick here. I can take the square root of 189, and that would give me about 13.74. So I could go to the next highest whole number, which would be 14, and I could test all the prime numbers. So I could start with 2 and go 2, 3, 5, 7, 11, and then 13. 14 is a composite number. I wouldn't need to check that. So it's not divisible by 2 because it's not even. So I can cross that out right away. Is it divisible by 3? Well, 1 plus 8 is 9, 9 plus 9 is 18. 18 is divisible by 3, so yes, this number is composite. Next, we look at 1. 1 is going to fall into the category of neither. And the reason we put neither here is because in the definition of a prime number and in the definition of a composite number, it specifically states that we're looking at whole numbers larger than 1. So 0 and 1 are excluded. If you get this question on a test, you just put neither. What about 17? So the square root of 17 is about 4.12. So just go to the next highest whole number, that would be 5. So I would test all the prime numbers up to and including 5. So 2, 3, and 5. I don't need to check 2 because this number is not even. Is 17 divisible by 3? 1 plus 7 is 8. 8 is not divisible by 3. So 17 is not divisible by 3. And the final digit of the number is not a 0 or a 5. So it's not divisible by 5. 17 is a prime number. This is a prime number. All right, so now we want to use a factor tree to find the prime factorization of each number. So we're going to start out with 100. So to build a factor tree, I start by just writing the number, and I extend what are called two branches, basically just two lines coming underneath the number. And I think of any two factors for that number. Doesn't matter what they are. 100 I could think of as 25 times 4, or I could do 10 times 10, or I could do 2 times 50. It doesn't matter. You're going to end up with the same answer at the end. So let's do 4 times 25. Now the next thing we do is we check to see if either number is prime. 4 is not prime. It's divisible by 2. 25 is not prime. It's divisible by 5. So then what we do is we just repeat the process under each number. So 4 I'm going to write as 2 times 2. Now 2 is prime, so I'm going to just stop and circle those. Okay, now I'm going to stop. I'm going to look at 25. I'm going to extend the branches and just repeat the process. 25 is 5 times 5. Now 5 is a prime number, so I'm going to circle each one and I'm going to stop. Now once I've stopped everywhere, I have nothing else to continue. I'm not repeating anywhere. I've found the prime factorization for the number. So we have 100 is 2 times 2 times 5 times 5, or 2 squared times 5 squared. What about 230? Again, write your number, 230, and then extend your two lines below the number. Again, those are called branches. Now, if something ends in a 0, meaning it has a trailing 0, we can divide it by 10. If I divide by 10 and I have a trailing 0, just cut the 0 off. So I'd have 23 times 10. Now, is 10 a prime number? No, it's not. 10 is 5 times 2. Both 5 and 2 are prime, so I'm going to circle those. Is 23 a prime number? Well, it is, but you might not know that. So punch up square root of 23 on your calculator. You'll get about 4.79. Go ahead and just think about the next highest whole number. That's 5. And again, test all the prime numbers up to and including 5. I don't need to test 2 because it's not an even number. 3 I would test with 2 plus 3, that's 5. 5 is not divisible by 3. The number does not end in a 0 or 5, so it's not divisible by 5. So yes, this is a prime number. I can circle it and stop. So I have my prime factorization for 230. It is 5 times 2 times 23. What about 936? 936. So the number's even. It's definitely divisible by 2. 36, the last two digits of the number, divided by 4 gives me 9, no remainder. So it's divisible by 4. 9 plus 3 is 12. 12 plus 6 is 18. 18 divided by 3 is 6, no remainder. So I know it's divisible by 12. Let's start with that. Right? Because if a number is divisible by 4 and 3, it's divisible by 12. So if I don't know what number times 12 gives me 936, I can find that with a long division. My result will give me my missing number over here, right? Because this times this gives me this. So 12 goes into 93 how many times? Well, 7 times. 7 times 12 gives me 84. We're going to subtract. 13 minus 4 is 9. Bring down the 6. 12 goes into 96 8 times. 8 times 12 is exactly 96. So the missing number is 78. 12 times 78 will give me 936. 12 is not prime. 78 is not prime. The way I know that is they're both even numbers. 12 I know off the top of my head is 4 times 3. 4 times 3. We know at this point 3 is prime, so you can go ahead and circle that. 4 is 2 times 2. 2 is prime, so you can circle those. What about 78? Well, I know at this point I can at least divide it by 2. 7 plus 8 is 15. 15 divided by 3 is 5, no remainder. So it's divisible by 2, it's divisible by 3, it's got to be divisible by 6. So what is 78 divided by 6? 6 goes into 7 once, 1 times 6 is 6. Subtract and get 1, bring down the 8. 6 goes into 18 3 times, 3 times 6 is 18. Subtract and get 0. So I would get 6 times 13. I know that 6 is 3 times 2. 3 and 2 are each prime numbers. What about 13? Is that a prime number? Well, yes. But again, if you didn't know that, you could punch up square root of 13 on a calculator. You'd get about 3.6. Now, the next highest whole number would be 4. If you test all the prime numbers up to and including 4, 4 is not a prime number, so you don't have to worry about that. You don't have to worry about 2 because this is an odd number. You really just have to test 3. So 1 plus 3 is 4. 4 is not divisible by 3. So yes, this is a prime number. So for the prime factorization, we look at the circled numbers. So 936 is equal to, we have 1, 2, 3 factors of 2. So that's 2 cubed. Times 1, 2 factors of 3. So that's 3 squared. Then times 13. Okay, what about 1,700? 1,700. So we have some trailing zeros here. And what's interesting is that, again, when we multiply with trailing zeros, so let's say I did 17 times 10. I know I would have 170, right? Multiply 17 times 1, attach a trailing 0. If I was multiplying by 100, I would just attach 2 trailing zeros. So we can see here that 17 times 100 would be 1,700. Another way to think about this is if I'm dividing a number and it has trailing zeros, if I divide by 10, I cut off 1 trailing 0. If I divide by 100, I cut off 2 of them. So if I have 1,700, again, and I divide by 100, I get 17. So this is 17 times 100 to produce 1,700. Now, you might stop and say, I don't work with 17 that often. Is it a prime number? Well, take the square root of it. You're going to get about 4.12. So the next highest whole number would be 5. Now, if I think about what prime numbers I need to check, I can exclude 2 because this number is not even, so I don't need to check it. Think about 3. 1 plus 7 is 8. 8 is not divisible by 3. The number does not end in a 0 or 5, so it's not divisible by 5. So yeah, this is a prime number. We can circle this and stop. What about 100? 100 you could write as 10 times 10. Or again, you could have done 25 times 4 or 2 times 50. It doesn't matter. You'll get the same answer either way. Now 10 is 5 times 2. And we know that 5 and 2 are both prime. So we're going to circle all of them. So now we found our prime factorization. 1,700 is equal to, we have 2 factors of 2, or 2 squared. We have 2 factors of 5, or 5 squared, and then times 17. What about 535? 535. So it ends in a 5. Let's start there. What if I divide by 5? 535 divided by 5. 5 goes into 5 once. 1 times 5 is 5. Subtract and get 0. Bring down the 3. 5 is not going to go into 3, so we put a 0. 0 times 5 is 0. Subtract and get 3. Bring down the 5. 5 goes into 35 7 times. 7 times 5 is 35. Subtract and get 0. So 107 times 5 gives me 535. Now, I know that 5 is a prime number. I have no idea about 107. So I'm going to use my square root trick. So if you take the square root of 107 on a calculator, you're going to get about 10.34. So go to the next highest whole number, that's 11. So we're thinking about all the prime numbers up to and including 11. So that's 2, 3, 5, 7, and 11. Looking at 107, I can exclude 2. I know that it's not divisible by 2 right away because it's not an even number. 1 plus 0 plus 7 is 8. 8's not divisible by 3. You can cross that out. The final digit of the number is not a 5. And it's also not a 0, so it's not divisible by 5. Now I need to check 7 and 11. And the rules are kind of elaborate for those. So either you can just straight divide it by 7 and see if it works. Divide it by 11, see if it works. Or you can use the trick. It doesn't matter. So let's just do the trick so we get some practice. So for 7, remember we cut off the final digit of the number. And we get 10 we would double it. 7 times 2 is 14. And we'd subtract. So 10 minus 14 is negative 4. That's not divisible by 7. Cross that out. What about 11? So again, you number the digits. So this is 1, 2, and 3. So you'd sum the digits in the odd places. So 1 plus 7 is 8. You would subtract away the sum of the digits in the even places. So I just have a 0. And that gives me 8. So that's not divisible by 11, and it's not 0. So it's not going to be divisible by 11. So 107 is a prime number. So the prime factorization for 535 is 5 times 107. Okay, so I saved the best for last. We have 51,480. 51,480. So where do we start? If you get something big on a test like this, use your divisibility rules. Just think about anything you can think of. I know it's even, so it's divisible by 2. I know it ends in a 0, so it's divisible by 5, and it's divisible by 10. 5 plus 1 is 6. 6 plus 4 is 10. 10 plus 8 is 18. 18 plus 0 is still 18. So I know it's divisible by 3. The last two digits of the number form the number 80. That's divisible by 4. 80 divided by 4 is 20, no remainder. So it's divisible by 12. So I can start with 12 if I want. Let's start with 12. So 51,480 divided by 12 is going to give me what? So 12 goes into 51 4 times. 4 times 12 is 48. Subtracting, get 3. Bring down the 4. 12 goes into 34 twice. 2 times 12 is 24. Subtracting, get 10. Bring down this 8. 12 goes into 108 9 times. 9 times 12 is 108. Subtracting, get 0. Bring down the 0. 12 goes into 0 0 times. So 4,290 times 12. 4,290 times 12 gives me 51,480. Okay, so 12 I can write as 4 times 3. 3 is prime. I'm going to circle that and stop. 4 I'm going to write as 2 times 2. Circle the 2. Circle the other 2. What about this 4,290? It ends in a 0, so I know it's not prime. I can divide it by 10. I could write it as 429 times 10. Again, if you divide this by 10, just cut the 0 off. So you get 429 times 10. So 10 I know is 5 times 2. 5 and 2 are both prime. What about 429? Do we have any idea or any clue if this is a prime number or not? I know it's not even. If I kind of think about 4 plus 2, that's 6. 6 plus 9 is 15. 15 is divisible by 3. So I know it's not prime because it's divisible by 3. So let's try that. Let's do 429 divided by 3. 3 goes into 4 once. 1 times 3 is 3. Subtract and get 1. Bring down the 2. 3 goes into 12 4 times. 4 times 3 is 12. Subtract and get 0. Bring down the 9. 3 goes into 9 3 times. 3 times 3 is 9. Subtract and get 0. So 143 times 3. 143 times 3. Now I know that 3 is prime. I'm going to circle that. So what about 143? So 143 is 11 times 13. Now we know already that 11 is a prime number, and you should know that 13 is. But again, if you don't, use the square root trick. You will find that 13 and 11 are both prime numbers, and so we're done. The prime factorization, and let me scroll up here real quick, for 51,480, 51,480, we have 1, 2, 3 factors of 2. So 2 to the third power, otherwise known as 2 cubed. We have 1, 2 factors of 3. So times 3 squared. We have 1 factor of 5, so times 5. We have 1 factor of 11, 1 factor of 13. So 2 cubed times 3 squared times 5 times 11 times 13. Hello and welcome to Pre-Algebra Test Section 1 on factoring whole numbers. All right, so we just want to determine if each number is prime, composite, or neither. So before we begin, what is the definition of a prime number? A prime number is a whole number that is larger than 1 that is only divisible by itself or 1. A composite number is a whole number that is larger than 1 that is divisible by something other than 1 or itself. So when I look at 17, is it going to be prime or is it going to be composite? What we can do is we can check the divisibility of 17 by each number, starting with 2, right, we'd exclude 1, and going all the way up to 16, right? We wouldn't include 17 because that's the number itself. But there's a shortcut, right? We don't need to go through all this work. What we can do is take the square root of 17. Once we have that number, we look at the next highest whole number. So the square root of 17, if you punch that up on your calculator, is about 4.12. So the next highest whole number would be 5. So all I need to do is check the divisibility by each prime number up to and including 5. So that would be 2, 3, and 5. Now I don't need to look at 2 because 17 is not even. It's an odd number, so it's not going to be divisible by 2. 3, I can check that. 1 plus 7 is 8. 8 is not divisible by 3. 5, I can check that. The number does not end in a 0 or a 5, so it's not divisible by 5. So I've checked all I need to check. This is going to be a prime number. What about 1? 1 falls in the category of neither. You might say, well, why is that the case? When we looked at the definition of a prime number and of a composite number, we saw that in each case we said a whole number larger than 1. Right? A prime number is a whole number larger than 1 that is divisible by itself or 1 only. A composite number is a whole number larger than 1 that is divisible by something other than itself and 1. In each case we said whole number larger than 1. So when we have 1 or we have 0, we just put neither, right? Because it's not prime and it's also not composite. What about 150? Well, because I look at this number and I know that it's even, I know that it's going to be a composite number. Because all even numbers that are larger than 2 are automatically composite numbers. They're divisible by 2. What about 12? Again, this is composite because it's even. What about 13? Well, if you punch up square root of 13 on a calculator, you get about 3.6. So the next highest whole number would be a 4. Now 4 is not a prime number, so all I really need to check would be 2 and 3. So it's not divisible by 2 because it's an odd number. I can check 3. 1 plus 3 is 4. 4 is not divisible by 3. So this is a prime number. What about 23? Well, punch up the square root of 23 on a calculator. You're going to get about 4.79. The next highest whole number is 5. So I'm going to look at 2, 3, and 5. And again, I don't need to check 2 because this is an odd number. So if I look at 3, 2 plus 3 is 5. 5 is not divisible by 3. If I look at 5, the number does not end in a 0 or a 5. So really, this is a prime number. This is a prime number. What about 110? Well, this is an even number, right? It ends in a 0. So this is going to be composite. Hello and welcome to Pre-Algebra Test Section 2 on factoring whole numbers. All right, so we want to write each as a product of prime factors, and we're going to be using a factor tree to do that. So we start out with 135. So to use a factor tree, you just write the number, and you extend two what we call branches underneath, and you list any two factors for the number. Now, I don't know any factors for 135 off the top of my head, but using my divisibility rules, I see that the final digit is a 5, so I know 135 is divisible by 5. So let me divide it by 5 and see what my missing factor would be. 5 goes into 13 twice. 2 times 5 is 10. Subtracting, get 3. Bring down the 5. 5 goes in 35 7 times. 7 times 5 is 35. Subtracting, gets 0. So 27 times 5 would give me 135. So let's start with that. Now, anytime I have a prime factor, meaning a factor that is a prime number, I just circle it and I stop. Anytime I have a factor that's not prime, I just repeat the original process. I put two branches underneath and then I list two factors for the number. So for 27, I could list 9 times 3. 9 times 3. Now, 3 is a prime number, so I'll circle that and stop. And 9 is not, so I'm going to continue. So put two more branches, and it's 3 times 3. So 3 is prime, so we're going to circle both of these, and we're done. We have 3 times 3 times 3 times 5. So 135 is equal to 1, 2, 3 factors of 3, or 3 cubed times 5. Okay, we're going to look at 1,800. So 1,800. So the cool thing about having two trailing zeros tells me that this number is divisible by 100. Right? If I have one trailing zero, it's divisible by 10. If it has 2, it's divisible by 100. So essentially, to divide this number by 100, I just cut off 2 zeros. So it would be 18 times 100. That would give me 1800. Right? If I multiplied 18 times 1 is 18, attached 2 trailing zeros, I'd get 1800. Now, 18, I know I can do 6 times 3. 6 times 3. And 3 is prime. 6 is 2 times 3. Both 2 and 3 are prime, so I'm going to circle those. And then for 100, let's do 10 times 10. 10 is 5 times 2. So let's circle the 5, the 2, the 5, and then the 2. Those are all prime. So now we're done. And we can list our prime factorization for 1800 as we have 1, 2, 3 factors of 2, so 2 cubed, times we have 1, 2 factors of 3, so 3 squared, times we have 1, 2 factors of 5, so 5 squared. So 2 cubed times 3 squared times 5 squared gives you 1800 or 1800. Hello and welcome to Pre-Algebra Test Section 3 on factoring whole numbers. All right, we want to write each as a product of prime factors. Another way you could say that is we want to find the prime factorization for each number, and we're going to be using a factor tree to do that. All right, so we begin with 680. So to make a factor tree, you just list the number, and then you put 2 branches, is what they're called, underneath the number. So the branches are so that you can list 2 factors, and this can be any 2 factors, for the original number. Now I see that this number is divisible by 10. So if I divide 680 by 10, I would get 68. So 68 times 10 gives me 680. Again, if you take a number that has a trailing 0, you divide it by 10, just cut the 0 off. That's how you get your answer. So for 10, it's 5 times 2. Now because 5 and 2 are both prime, we circle them. We circle them. That tells me to stop, okay, because I've found the prime factors there. But over here for 68, I can keep going. 68 is not a prime number. Now, I know that 68 is divisible by 2, but it might also be divisible by 4. Let's check that out. 4 goes into 6 once. 1 times 4 is 4. Subtract and get 2. Bring down the 8. 4 goes into 28 7 times. 7 times 4 is 28. Subtract and get 0. So 17 times 4 is 68. 17 times 4 is 68. Now, I know that 4 is not prime, but is 17 prime? Well, at this point, you should probably know that 17 is prime, but if not, you can check it. Punch up the square root of 17 on your calculator. You'll get about 4.12. Go to the next highest whole number. That would be 5. And check all your prime numbers up to and including 5. So is 17 divisible by 2? No way, right? It's an odd number. Is 17 divisible by 3? 1 plus 7 is 8. 8 is not divisible by 3, so no. Is it divisible by 5? Well, the last digit of 17 is a 7. To be divisible by 5, it needs to be a 0 or a 5. So it fails. So this is a prime number. Now for 4, we know that's 2 times 2. And 2 is a prime number, so we're going to circle each. Now we're done, right? We don't have anything else to continue on. So we just list the prime factorization of 680. We have 1, 2, 3 factors of 2. So that's 2 cubed times 5 times 17. All right, what about 12,600? So 12,600. So I know this is divisible by 100 because it has 2 trailing zeros. And to divide a number with 2 trailing zeros by 100, just cut those 2 trailing zeros off. You'd have 126 times 100. I know that 100, I could write that as 10 times 10. And then 10 is 5 times 2. 5 is prime, 2 is prime, so we're going to circle each. And we're done over here. Now we're going to focus on 126. Now I know that that's an even number, so I know it's at least divisible by 2. Let's see if we can do better. So what is 126 divided by 6? 6 goes into 12 twice. 2 times 6 is 12. Subtract and get 0. Bring down the 6. 6 goes into 6 once. 1 times 6 is 6. Subtract and get 0. So this would be 21 times 6. Now I know 6 is 3 times 2. 3 and 2 are both prime. Circle those. And 21 is 7 times 3. 7 and 3 are both prime. So now I have my prime factorization. So 12,600 is equal to, I have 1, 2, 3 factors of 2, so 2 cubed, times I have 1, 2 factors of 3, so 3 squared, times I have 1, 2 factors of 5, so 5 squared, and then times 7. Hello and welcome to Pre-Algebra Test Section 4 on factoring whole numbers. All right, so we just want to write each as a product of prime factors, meaning we want to find the prime factorization for each number. And what we're going to do is we're going to use a factor tree to do that. Okay, we're going to begin with 468. So to make a factor tree, you just start by extending to what we call branches, and then you list two factors for the number. It could be any two factors. You put one under each branch. I know it's an even number, so I know it's divisible by 2. So I could start with that if I wanted to, or I could try to divide by something higher. So 68 is divisible by 4. 68 divided by 4 is 17. So I could do that, but I would probably go with 12. If you look at the number, 4 plus 6 is 10, 10 plus 8 is 18, 18 divided by 3 is 6, no remainder. So if a number is divisible by both 4 and 3, it's divisible by 12. So what is 468 divided by 12? Well, I have no idea, so let's do the long division. 12 goes into 46 3 times. 3 times 12 is 36. Subtract, you get 10. Bring down the 8. 12 goes into 108 9 times. 9 times 12 is 108. Subtract and get 0. So 12 times 39 is 468. Now, neither number is prime, so what I'm going to do is I'm going to continue. I'm basically just going to repeat what I did. So 12 I could write as 4 times 3. And I check to see if either number is prime. Now, 3 is prime, so what I do when I have a prime number is I circle it. And I stop. I don't need to repeat anything there. I'm done. 4 is not prime, so I continue. So 4 I'm going to write as 2 times 2. And 2 is prime, so I circle each one, and I'm done. Now I focus on 39. The reason I know 39 isn't prime, 3 plus 9 is 12. 12 divided by 3 is 4, no remainder. So I know it's divisible by 3. 39 divided by 3, in case you don't know, is 13. Now 3 is prime. I know that. The question is 13 prime? A lot of you might not have worked with 13 before. It is prime. But again, if you want to check it, punch up the square root of 13 on your calculator. You'll get about 3.6. Okay, approximately 3.6. So go to the next highest whole number. That would be 4. So all you need to do is check all the prime numbers up to and including 4. Now 4 is not a prime number, so you don't need to check that one, but it would be up to and including 4. I don't need to check 2 because that's obviously not going to work. This is an odd number. So I would just check 3. 13 is not divisible by 3. 1 plus 3 is 4. 4 is not divisible by 3. So 13 is not divisible by 3. So this is in fact a prime number. So now that we don't have anywhere to continue with, we're done. Your prime factorization for 468 is the product of the circled numbers. So 2 times 2, which is 2 squared, times 3 times 3, which is 3 squared, times 13. All right, let's take a look at one more. I have 3,420. So again, write the number and extend 2 branches. And this one's easy because it ends in 0. So I know it's divisible by 10. And if I divide a number with a trailing 0 by 10, I just cut off the 0. So it would be 342 times 10. Now 10 is not prime and neither is 342, so we continue. 10 is 5 times 2. 5 and 2 are both prime, so we're going to circle them and stop. 342 is even, so I know it's at least divisible by 2. I also know that it's divisible by 3. 3 plus 4 is 7. 7 plus 2 is 9. 9 divided by 3 is 3, no remainder. So it's definitely divisible by 6. So let's go with that. 342 divided by 6. 6 goes into 34 5 times. 5 times 6 is 30. Subtract and get 4. Bring down the 2. 6 goes into 42 7 times. 7 times 6 is 42. Subtract and get 0. So 6 times 57 would give me 342. Now I know that 6 is 3 times 2. And 3 and 2 are each prime, so I can circle those and stop. I don't work with 57 very often, so I don't know if it's prime or not. So check if it's divisible by any of the prime numbers, starting with 2, going up through 8, and 8's not a prime number. So you would have what? You'd have 2, 3, 5, and 7. So it's not divisible by 2. 5 plus 7 is 12. 12 divided by 3 is 4, no remainder. So yeah, it's not going to be a prime number. So what is 57 divided by 3? 3 goes into 5 once. 1 times 3 is 3. Subtract and get 2. Bring down the 7. 3 goes into 27 9 times. 9 times 3 is 27. Subtract and get 0. So 57 is 19 times 3. So 3 is prime. We can circle that and stop. But what about 19? Well, it is a prime number, but in case you didn't know that, so check all your prime numbers up to and including 5. So is 19 divisible by 2? No, because it's not even. It's not divisible by 3. 1 plus 9 is 10. 10 is not divisible by 3. And it's not divisible by 5 because it doesn't end in a 0 or a 5. So 19 is a prime number. So now we're done. We found the prime factorization for 3,420. And it's just the product of the circled numbers. So I'd have 2 factors of 2, or 2 squared. I'd have 2 factors of 3, or 3 squared. I'd have 5, and I'd have 19. So 2 squared times 3 squared times 5 times 19 gives me 3,420. Hello and welcome to Pre-Algebra Test Section 5 on factoring whole numbers. All right, so we want to write each as a product of prime factors. And what that means is we're trying to find the prime factorization of each number involved. And the method we're going to use is we're going to use a factor tree. So we're starting out with 10,296. So just write the number, 10,296. And with a factor tree, you start out by extending 2 what we call branches underneath the number. And then you're going to list any 2 factors that you want. So look at the number and think about your divisibility rules. I know that it's an even number, so it's divisible by 2. If I sum the digits, 1 plus 0 plus 2 plus 9 plus 6 is 18. 18 divided by 3 is 6 with no remainder. So if something's divisible by 2 and 3, it's definitely divisible by 6. But also, if something's divisible by 3 and 4, it's divisible by 12. Now, the final 2 digits of this number forms the number 96. 96 divided by 4 is 24. Since this number is divisible by both 3 and 4, it's divisible by 12. So let's just start with that. Now, I don't know what the missing factor is over here. The way I can get it is with long division. So 10,296 divided by 12. Whatever I get here would be my missing factor. 12 goes into 102 8 times. 8 times 12 is 96. Subtract. We're going to borrow there and borrow again. 12 minus 6 is 6. 9 minus 9 is 0. And that would be 0, so we just have 6 there. Now bring down this 9. 12 goes into 69 how many times? Well, 5 times. 5 times 12 is 60. Subtract and you get 9. Then we're going to bring down this 6 here. So how many times will 12 go into 96? Well, exactly 8. 8 times 12 is 96. Subtract and get 0. So 858 times 12, 858 times 12 is what gives me 10,296. Now, neither number is prime, so we keep going. 12 I can write as 4 times 3. Now, 3 is a prime number, so I circle it and I stop. That's what I do when I get a prime number. I just circle it and stop. 4 is not prime, so I continue. 4 is 2 times 2. 2 is prime, so I circle each and stop. Now I need to deal with 858. So I know it's an even number, so it's at least divisible by 2. 8 plus 5 is 13. 13 plus 8 is 21. So this number is divisible by 3 because 21 divided by 3 is 7. So if a number is divisible by both 2 and 3, it's divisible by 6. So let's go with that. So 6, and then finding the missing factor, I'll just do a long division. 6 goes into 8 once. 1 times 6 is 6. Subtracting, get 2. Bring down the 5. 6 goes into 25 4 times. 4 times 6 is 24. Subtracting, get 1. Bring down the 8. 6 goes into 18 3 times. 3 times 6 is 18. Subtracting, get 0. So 6 times 143. Okay, so 6 I know is 2 times 3. And each is prime, so I can circle and stop. But what about 143? Is that a prime number? We don't really work with that too often. Again, the trick I taught you in the lesson is punch up square root of 143 on your calculator. You're going to get about 11.9. Go to the next highest whole number, so go to 12. And I want you to test 143 divided by each prime number going up to and including the number that you come up with. In this case, it's 12. 12 is not a prime number, so you wouldn't have to worry about it. But you would basically test 2, 3, 5, 7, and 11. So 143 is not going to be divisible by 2. It's an odd number. 1 plus 4 is 5. 5 plus 3 is 8. Not divisible by 3. The last digit is 3, so it's not divisible by 5. For divisibility by 7, remember, you take and cut off the last digit, which is a 3. You double it and you subtract. So 14 minus 6 is 8. 8's not divisible by 7, so you can cross that one out. What about 11? Well, for 11, again, you number the digits. So you say this is the first digit, the second digit, and the third digit. You're summing the digits in the odd position, so that would be 1 plus 3. And that's just a coincidence that they fall like that, but it's the number 1 and the number 3 that are in the first and the third position. So 1 plus 3 is 4. And then you subtract away the sum of the numbers in the even positions. So I just have one number in an even position, that's 4. So I subtract that away, and I get 0. Now, because this is a 0, I know that this number is divisible by 11. Right? If I get a 0 or a number that's divisible by 11, the number is divisible by 11. So 143 will have 11 as a factor. So 143 divided by 11. 11 goes into 14 once. 1 times 11 is 11. Subtracting, get 3. Bring down the 3. 11 goes into 33 3 times. 3 times 11 is 33. Subtracting, get 0. So 11 times 13 gives me 143. Now, we do know at this point, or we should know, that 11 and 13 are each prime numbers. So we can circle those and stop. If you didn't, again, you can use that little square root trick. So I am done here. I have my prime factorization. So 10,296 is equal to, it's just the product of all the circled numbers. So I have 2 times 2 times 2. So 3 factors of 2. So 2 cubed. Times 3 times 3, that's 3 squared. Times 11 times 13. So 10,296 is 2 cubed times 3 squared times 11 times 13. All right, for the last problem, I have 2,205. So 2,205. Again, extend 2 branches underneath that number and use your divisibility rules. This number ends in 5, so I know it's divisible by 5. So 2,205 divided by 5. 5 goes into 22 4 times. 4 times 5 is 20. Subtracting, get 2. Bring down the 0. 5 goes into 24 times. 4 times 5 is 20. Subtracting, get 0. Bring down the 5. 5 goes into 5 once. 1 times 5 is 5. Subtracting, get 0. All right, so 441 times 5 gives me 2,205. Now, I know that 5 is a prime number, so I can circle that and stop. But what about 441? So if you punch up the square root of 441 on your calculator, you get 21. So when something like that happens, it tells you that the number's not prime, right? It's because it's divisible by 21. It's divisible by something other than itself or 1. So I can just write that this is 21 times 21. Now 21 is 7 times 3. 7 times 3. And 7 and 3 are both prime, so I can just circle all of these, and I'm done. So 2,205 is equal to, again, the product of the circled numbers. So I'd have 5 times, I have 2 factors of 3, so 5 times 3 squared, times, and I have 2 factors of 7, so 7 squared. So 2,205, again, is equal to 5 times 3 squared times 7 squared. Hello and welcome to Pre-Algebra Practice Set number 26. And in this video, we're going to look at some additional practice problems for our lesson on Introduction to Fractions. All right, so we're going to start out with this exercise where we identify the numerator and denominator in each. So we start out with 1 over 8, or 1/8. So remember, the numerator is the top part of the fraction. So it's the top number. It's the numerator. Right, so 1 is the numerator here. Then the bottom number is the denominator. So 8 is our denominator. All right, what about 3/5? So the top number of the 3 is the numerator. And I'm just going to write a capital N to represent numerator. And the bottom number 5 is the denominator. So I'm just going to put a capital D to represent denominator. For 9/14, the 9, the number on top, is the numerator. The 14, the number on the bottom, is the denominator. For 12/17, 12, the number on the top, is the numerator. 17, the number on the bottom, is the denominator. For 6/11, 6, the number on the top, is the numerator. 11, the number on the bottom, is the denominator. For 4/9, the 4, the number on top, is the numerator. And the 9, the number on the bottom, is the denominator. All right, so that was very, very simple. Let's move on to the next part. We want to write each division problem using a fraction, then perform the division. So we begin with 27 divided by 9. So basically, when you write this as a fraction, you just think about it as the numerator divided by the denominator. So it's this part, the leftmost number of the division problem is the numerator. You have your fraction bar, and then the rightmost part of the division problem is your denominator. All right, it's 27 divided by 9. Same goes when you have the fractions. 27 over 9, or 27 divided by 9. Again, this fraction bar is representing division. So what is 27 divided by 9? Well, this is 3. Now we have 35 divided by 7. Again, this number on the left, the 35, that's going to be your numerator, because we're going to have 35 divided by, and then we have this 7. So 35 divided by 7, you write as 35 over 7, and if we divide 35 by 7, we get 5. All right, for the last one, we have 55 divided by 11. Again, 55, this left number, that's going to be your numerator, and then divided by, we have 11, that's going to be your denominator. So 55 divided by 11 is 5. All right, now we want to write a fraction that represents the shaded part and non-shaded part of each picture. All right, so we're going to start out by looking at this circle here. So the circle has 8 equal parts. So let's just number them. We have 1, 2, 3, 4, 5, 6, 7, 8. And remember, our goal is to make fractions that represent the shaded part and the non-shaded part. So for the shaded part, what's our fraction going to be? Well, in each case, for the shaded part and the non-shaded part, the denominator is going to be 8. Right? The denominator is going to be 8. How do I know that? The denominator tells you how many equal parts you've split this whole amount into. You consider this circle as just one whole amount. And we split it up into 8 equal parts or 8 equal pieces. So the denominator in each case is going to be 8. Now, how do we get the numerator for each? Well, for the shaded part, I would just count up how many parts are shaded out of the 8. I have 1, 2, 3, 4, 5. There are 5 parts that are shaded, so the numerator is going to be a 5. So the shaded part is 5/8, or 5 out of a total of 8 that are shaded. What about the non-shaded part? Well, you could use some simple subtraction and say, well, if 5 parts are shaded out of the 8, that means that 8 minus 5, or 3 parts, are not shaded. Or you can go through and count them. You can say, okay, I have 1, 2, 3 parts that are not shaded. So this would be the fraction 3 over 8, or 3/8, right? 3 parts out of a total of 8 are not shaded. Here we have a rectangle. So this is split up into 1, 2, 3, 4, 5, 6 equal parts. So what's our shaded going to be? Shaded and non-shaded. Well, in each case, the denominator is going to be 6, right? Because we have a total of 6 equal parts. 6 equal parts. So in each case, the denominator is 6. So for shaded, I have one part, right? One part that's shaded. So it's going to be 1/6. That's the portion that is shaded of this rectangle. For the non-shaded, I have 1, 2, 3, 4, 5 parts that are not shaded out of a total of 6. So 1/6 of the rectangle is shaded, right? Or one piece out of 6 total pieces. And 5/6 of the rectangle is not shaded, right? Or 5 pieces, again, out of a total of 6. All right, for the last exercise, we want to identify each as a proper fraction, improper fraction, or mixed number. So we begin with 3 over 52. So is this proper, improper, or a mixed number? Well, we know it's not a mixed number because there's no whole number off to the left. So we just have narrowed this down to either a proper fraction or improper. Proper fractions have a numerator that is less than the denominator. So if we think about 3, it's less than 52, so this is a proper fraction. What about 27 over 40? The numerator here, 27, is less than the denominator, 40, so this is proper. What about 1 and 1/4? Well, we have a whole number off here to the left, so we know this is a mixed number. This is a mixed number. And a mixed number always has a whole number and a proper fraction. So 1/4, the 1 is smaller than the 4, that's a proper fraction. 1 and 1/4 is a mixed number. What about 11/15? The 11 is smaller than the 15. Numerator smaller than the denominator. This is a proper fraction. What about 19 over 13? The numerator is now bigger than the denominator, so this is an improper fraction. Here we have 13 over 5. Numerator is bigger than the denominator, so this is improper. What about 25 over 7? Numerator is bigger than the denominator, so this is improper. And we'll kind of wrap it up with 9 7/10. We have a whole number off to the left here with a proper fraction. This is a mixed number. Hello and welcome to Pre-Algebra Test Section 1 on Introduction to Fractions. So we want to identify the numerator and denominator in each. So we start out with the fraction 3/7. So remember, the numerator is the top part and the denominator is the bottom part. So the 3 is on top, that's the numerator. And the 7's on the bottom, that's the denominator. Next we look at 4/15. The 4's on top, so that's the numerator. And I'm just going to write an n there to represent numerator. And the 15's on the bottom, that's the denominator. I'm just going to put a d there to represent denominator. Next we have 12/11. So the 12, the number on top, is the numerator. The 11, the number on the bottom, is the denominator. Then we look at 9/8. 9, the number on top, is the numerator. 8, the number on the bottom, is the denominator. What about 2/3? 2, the number on top, is the numerator. 3, the number on the bottom, is the denominator. What about 24/5? 24, the number on top, is the numerator. 5, the number on the bottom, is the denominator. What about 4/3? 4, the number on top, is the numerator. 3, the number on the bottom, is the denominator. What about 3/4? 3, the number on top, is the numerator. 4, the number on the bottom, is the denominator. Hello and welcome to Pre-Algebra Test Section 2 on the Introduction to Fractions. Okay, so we want to write each division problem using a fraction, then perform the division. So we start out with 81 divided by 9. So in a division problem, this left number here would be the numerator. So this is 81. Then instead of this symbol here, you're going to have a fraction bar. Again, the fraction bar represents division. And then you're going to have the right number of a division problem as your denominator. So 81 divided by 9 is the same as 81 divided by 9 like this, or 81/9, right? Again, this fraction bar represents division. So it's the numerator, again 81, divided by the denominator, which is 9. So now we just think about what is 81 divided by 9, and that's just 9. So for 72 divided by 8, we take this left number, that's going to be our numerator. We have our fraction bar, and then we have this right number, the 8, we put that as the denominator. So we have 72/8, and this is the same thing as saying 72 divided by 8. So 72 divided by 8 is 9. Now we have 54 divided by 6. So this left number, 54, is the numerator. Then we have our fraction bar, and then we have 6, that's going to be our denominator. So 54 divided by 6 is 9. Then we have 300 divided by 10. So again, the 300, the leftmost number, that's your numerator. And then we have our fraction bar, that represents the division. And then we have 10, that's going to be our denominator. So 300 divided by 10. If you have a number with trailing zeros, like 300, and you divide by 10, basically all you need to do is cancel one of the zeros. So this would be 30. And you can think about why that works with multiplication. If I had 30 times 10, really I have trailing zeros here. Think about just starting with 30 times 1. I know we normally do 3 times 1, but just think about 30 times 1, that's 30, and then attach one trailing zero. So if I reverse that and I said 300 divided by 10, I'm really just canceling one of the zeros away. All right, for the last problem, we have 180 divided by 60. So the left number, again, is going to be your numerator. Then we have our fraction bar that represents division. And then we have 60, that's going to be our denominator. And then we just do the division. 180 divided by 60 is 3. Hello and welcome to Pre-Algebra Test Section 3 on the Introduction to Fractions. So we want to write the fraction that describes the shaded part and non-shaded part of each illustration. So when we look at this circle, we see that it's split up into 4 equal parts. So we have 1, 2, 3, 4 equal parts. Our goal is to write a fraction to describe the shaded part, and a fraction to describe the non-shaded part. So in each case, the denominator will be the same, right? The denominator represents the total number of equal parts you have split your whole amount into. In this case, we have 1, 2, 3, 4. total pieces involved or total parts involved. So let's put a 4 as the denominator for each. And then to get the numerator in each case, it's just what you're discussing. So if I'm discussing the shaded part, I look to see how many pieces I have that are shaded. Well, I only have 1, so that's my numerator. So 1 out of 4 pieces is shaded. So that's the fraction 1/4, right? 1/4 of this circle is shaded. Then for the non-shaded part, I have 1, 2, 3 of those. So 3 out of a total of 4, right? Or the fraction 3/4. So the shaded part is 1/4. The non-shaded part is 3/4. All right, next we have a rectangle that's split up into 1, 2, 3, 4, 5, 6, 7, and then 8 equal parts. So again, we're looking for the non-shaded and the shaded. So the shaded and the non-shaded. So in each case, the denominator will be 8, right? We took this rectangle and split it up into 8 equal parts. So the denominator in each case is an 8. And what's the numerator? Well, for the shaded, we have 1, 2, 3, 4, 5, 6, 7 parts that are shaded. So the numerator is a 7. Right? So we have 7/8 of this rectangle that's shaded. Then for the non-shaded, we only have 1. Right? We have 1 part out of a total of 8 parts. So 1 is my numerator. And again, 8 is the denominator. So the non-shaded portion of this rectangle is 1/8. Hello and welcome to Pre-Algebra Test Section 4 on the Introduction to Fractions. So we want to write the fraction that describes the shaded part and non-shaded part of each illustration. All right, so here we have a rectangle. And the rectangle is split up into 1, 2, 3 equal parts. So the shaded part, and the non-shaded part will have the same denominator, right? Because the denominator represents how many equal parts we've split that whole amount into. So in each case, the denominator is 3. So what about the numerator? In the case of the shaded part, we have 1, 2, 3 parts that are shaded. So 3 parts out of a total of 3 parts are shaded. And remember, this represents 1, right? 3 divided by 3 is 1. And that makes sense because the whole thing is shaded. What about the non-shaded part? Well, I have 0 parts that are not shaded. So really, this would be the fraction 0/3, which we know that 0 divided by a non-zero number is 0, so this is 0. All right, I'm saying that no parts of the 3 are non-shaded, which makes sense. If we look at this, nothing is not shaded. So realistically, I could not use fractions here and say that the entire thing is shaded and nothing is not shaded. What about this triangle here? Well, we have 2 sections. So we have this section and this section. So split up into 2 equal sections. So what's the shaded? And what's the non-shaded? Well, we know the denominator in each case is a 2. And the numerator in each case is going to be a 1, right? Because it's split into 2, so that means each section is 1/2, right? I have 1 part out of 2 that's shaded, and I have 1 part out of 2 that's non-shaded, so in each case we have the fraction 1/2. Hello and welcome to Pre-Algebra Test Section 5 on the Introduction to Fractions. All right, so we want to identify each as a proper fraction, improper fraction, or mixed number. We will begin with 17/18. So the basic rule is that if the numerator is smaller than the denominator, you're looking at a proper fraction. If the numerator is the same as or larger than the denominator, you're looking at an improper fraction. And then a mixed number is very easy to spot, right? You'll have a whole number part and then a proper fraction part. Those are easy to see. So this here with 17/18, 17 is smaller than 18, so this is a proper fraction. With 12/31, 12 is smaller than 31, so this again is a proper fraction. With 55/6, 55 is larger than 6, so this is an improper fraction. With 4/9 or 4/9, 4 is smaller than 9, so this is a proper fraction. With 8/3 or 8/3, 8 is larger than 3, so this is an improper fraction. With 1 and 1/17, you see you have this whole number out to the left and then a proper fraction. This is a mixed number. Here we have 6 and 5/7. Again, you have a whole number and then a proper fraction. This is a mixed number. What about 18 over 18? A lot of students get confused at this. If your numerator is the same as your denominator, that's actually an improper fraction. A lot of students think it has to be greater than. So they'll say, okay, well, 19 over 18 is improper, but they think 18 over 18 is proper. That's not true. 18 over 18 is still considered an improper fraction because the numerator is the same as the denominator. So if it's the same as or larger, it's improper. If it's less than, it's proper. Hello and welcome to Pre-Algebra Practice Set number 27. In this video, we're going to look at some additional practice problems for our lesson on mixed numbers and improper fractions. So we want to change each improper fraction to a mixed number or whole number. So for the first one, we're going to have 79/4. So when we have an improper fraction and we want to convert it to a mixed number, the first thing we do is we divide the numerator by the denominator. So we would divide 79 by 4. So 4 goes into 7 just once. 1 times 4 is 4. Subtracting, get 3. Bring down the 9. 4 goes into 39 9 times. 9 times 4 is 36. If we subtract here, we get 3. So remember, this 3 down here is known as our remainder. So we have 19 with a remainder of 3. So to write our mixed number, the first thing we do is we take our quotient part from the division. In this case, that's 19. We write that as the whole number for the mixed number. The next thing we do is we form the fraction part of the mixed number. The numerator for the fraction part is the remainder from your division. In this case, the remainder from our division is 3. So our numerator for the fraction part of the mixed number will be a 3. And then the denominator for the fraction part of the mixed number is just the same denominator from the improper fraction. So 79/4 is equal to 19 and 3/4. Let's try another one. Let's say we have 31/7. So again, we're going to divide the numerator by the denominator. So we're going to have 31, and we're going to divide that by 7. So 7 will go into 31 4 times. 4 times 7 is 28. If we subtract here, let's borrow. This will become 2. This will become 11. 11 minus 8 is 3. And then 2 minus 2 is 0, so we just have 3. Remember, this is your remainder. So this is 4 with a remainder of 3. So now that we've done our division, we can go ahead and write our mixed number. So again, the quotient part, which in this case is 4, that's going to be my whole number part for the mixed number. So the whole number part for the mixed number is a 4. Then my remainder, which in this case is a 3, that's going to be the numerator for the fraction part of the mixed number. And then the denominator for the fraction part of the mixed number is just the 7, right? It's just the same denominator as from the improper fraction. So 31/7 is equal to 4 3/7. All right, for the next one, we have 5/5. And just recall that the official definition for an improper fraction says that you have an improper fraction if the numerator, which in this case it's a 5, is the same as or greater than your denominator. Here, this 5 is the same as the 5 in the denominator, so we have an improper fraction. But when you get something like this on a test, it's really, really easy to get an answer because any non-zero number over itself or any non-zero number divided by itself is just 1. So 5/5 or 5 over 5 or 5 divided by 5 is 1. What about 12/11? Well, again, let's set up our long division. So 11 goes into 12 once. 1 times 11 is 11. We would subtract here and get 1. So this is 1 with a remainder of 1. And so to set up our mixed number, we'd have 1. The quotient part of the division serves as our whole number part for the mixed number. Then 1, which is our remainder in this case, is going to be the numerator for the fraction part. And then the denominator for the fraction part is 11. Right? It's the same denominator as we have for the improper fraction. So 12/11 is equal to 1 1/11. All right, let's go over one final problem, and then we're going to look at some practice problems for converting a mixed number into an improper fraction. So we have 97/13. So divide the numerator, 97, by the denominator, 13. Now 13 goes into 97 how many times? We don't work with 13 to 97 very often, so this is where we kind of have to guesstimate a little bit. I know that 13 times 10 is 130. And that's obviously too big, but it's an easy starting point because I'm multiplying by 10. All I need to do is take the number and put a 0 at the end. Now, if I think about, okay, times 9 would still be too big, times 8 would still be too big. Let's try 13 times 7. I think that would be perfect. So 13 times 7. 7 times 3 is 21. 7 times 1 is 7, plus 2 is 9. That gets me to 91. That looks like it's absolutely perfect because if I add 13 to 91, I get 104. That's too big. So let's put a 7 here. Again, 7 times 13 is 91. If we subtract, we'll get 6. So let's drag that up here and put remainder of 6. And my mixed number here, remember the whole number part is going to be the quotient from your division. So that's a 7. Then the remainder, which in this case is a 6, is going to be the numerator for the fraction part. And then your denominator for the fraction part is the same as the denominator from the improper fraction. So this would be over 13. So 97/13 is equal to 7 6/13. Okay, so now let's get some practice going from a mixed number to an improper fraction. So we want to change each mixed number to an improper fraction. We're starting out with 27 1/3. So the procedure for this, you just start out by taking your denominator from the fraction part and multiplying it by the whole number part. So essentially I'm going to say, what is 3 times 27? When I'm done with that operation, I add to this the numerator from the fraction part. So I'm going to add a 1 to that. And then this is over. My denominator is going to be the same as the denominator from the fraction part of the mixed number. So this is over 3. So what is 3 times 27? So a lot of you will need to do a vertical multiplication for that. So let's check that out. 3 times 7 is 21. 3 times 2 is 6, plus 2 is 8. So that is 81. Now if I add 81 and 1, I get 82. So this is going to be 82 over 3, or 82/3. So we can say that 27 1/3 is equal to 82/3. What about 12 1/8? Well, again, what we're going to do is we're going to multiply this 8, the denominator from the fraction part, by 12, the whole number part. So we have 8 times 12. And then when we're done with that, we're going to add the numerator from the fraction part. So I'm going to add a 1. This is all over the denominator from the fraction part. So it's all over 8. So what is 8 times 12? Well, a lot of you do know your times tables up to 12 times 12. You know that 8 times 12 is 96. If we add 1 to that, we get 97. And then this is over 8. So 12 1/8 is equal to 97/8. All right, what about 5 18/19? So again, I'm going to take my denominator from the fraction part, which in this case is 19, and I'm going to multiply it by the whole number part. So I'm multiplying by 5. When I'm done with this operation, I'm going to add to it the numerator from the fraction part. So plus 18, and this is all over the denominator from the fraction part, so over 19. So what is 19 times 5? Well, if I know that 20 times 5 is 100, if I know that 20 times 5 equals 100, right, using my trick for trailing zeros, 2 times 5 is 10, attach a 0 to the end, you get 100. What would 19 times 5 be? Well, it's just 5 less, right? It's 5 less, so it would be 95. So then I'd have 95 plus 18. 95 plus 18. 5 plus 8 is 13. 1 plus 9 is 10, plus 1 is 11. So I'd have 113 there in my numerator. And this is over 19. So 5 18/19 is equal to 113/19. Next, we're going to look at 3 49/50. So I'm going to take 50, the denominator from the fraction part, and multiply it by 3, the whole number part. So 50 times 3. Then when we're done, we're going to add 49, right? The numerator from the fraction part. And this is over the denominator from the fraction part, which is 50. So 50 times 3 is easy to do. We have a trailing 0 on 50. So 5 times 3 is 15. Put a 0 at the end, it's 150. So this is 150 plus 49 over 50. So what is 150 plus 49? So 150 plus 49. 0 plus 9 is 9. 5 plus 4 is 9. Bring down the 1. I get 199. So 199, and this is over 50. So 3 and 49 fiftieths is equal to 199 fiftieths. Okay, we have one final problem to do. So we have 17 and 13 fifteenths. So again, we're going to start out the same way. We take our denominator from the fraction part of the mixed number, which in this case is 15. We're going to multiply it by the whole number part, which is 17. When we're done with this operation, we add the numerator from the fraction part of the mixed number, so plus 13. And then our denominator is the same denominator from the fraction part of the mixed number, so that's 15. So what's 15 times 17? Let's do a vertical multiplication to get that. 7 times 5 is 35. 7 times 1 is 7, plus 3 is 10. And then 1 times 15 is 15. Bring this 5 down. 0 plus 5 is 5. 1 plus 1 is 2. So that's 255. Then we're adding 13. So that would be 268. So we'd have 268 over 15. So 17 and 13 fifteenths is equal to 268 fifteenths. Hello and welcome to Pre-Algebra Test Section 1 on mixed numbers and improper fractions. All right, so we just want to convert each improper fraction into a mixed number. We're going to start out with 9 fifths. So the procedure to do this is extremely simple. We just take the numerator and divide it by the denominator to begin. So we would take 9, again our numerator, and we divide it by 5, which is our denominator. So 5 goes into 9 only once. 1 times 5 is 5. Subtracting, we would get 4. So this division results in 1 with a remainder of 4. Now we kind of use this to build our mixed number. So we have 9 fifths here. This is going to be equal to, the whole number part of the mixed number is the quotient from your division. So that's going to be a 1. Now, the numerator for the fraction part is your remainder. So that's going to be a 4. So we're going to put a 4 here. And then the denominator for the fraction part of the mixed number is the same as the denominator from the improper fraction. So it's just going to be a 5. So 9 fifths is equal to 1 and 4 fifths. What about the fraction 3 halves? Well, again, we take our numerator and we divide by our denominator. So 2 goes into 3 once. 1 times 2 is 2. Subtracting, we get 1. So this division results in 1 with a remainder of 1. So the whole number part is your quotient from the division. So that's going to be 1. And then the remainder, which is also a 1, is your numerator for the fraction part of the mixed number. And then again, the denominator for the fraction part of the mixed number is the same as the denominator from the improper fraction. So that's going to be a 2. So 3 halves is equal to 1 and 1 half. Let's take a look at 11 ninths now. So we take our numerator, which is 11. We divide that by our denominator, which is 9. 9 goes into 11 once. 1 times 9 is 9. Subtracting, get 2. So this is 1 with a remainder of 2. So again, the whole number part is the quotient from your division. So that's going to be a 1. Then the numerator for your fraction part of the mixed number comes from the remainder. So the remainder is 2. So that's going to be the numerator for the fraction part of the mixed number. And then again, the 9, which is your denominator in the improper fraction, is going to be your denominator in the fraction part of the mixed number. So 11 ninths is equal to 1 and 2 ninths. Hello and welcome to Pre-Algebra Test Section 2 on mixed numbers and improper fractions. All right, so we want to convert each improper fraction into a mixed number. We're going to begin with 22 fifths. So again, a way to do this is you take your numerator and you divide it by the denominator. So I would take the numerator of 22 and divide this by my denominator, which is 5. 5 goes into 22 4 times. 4 times 5 is 20. Subtract and get 2. So we say that the result is 4 with a remainder of 2. Now, to set up your mixed number, you just need the information here. Your whole number part is going to be the quotient from your division. So that's going to be a 4. Your numerator in the fraction of the mixed number comes from your remainder, and that's going to be a 2. And then your denominator for the fraction in your mixed number comes from the denominator in the improper fraction. So we just kind of copy that, so that stays as a 5. So 22/5 is equal to 4 2/5. What about 17/3? Again, take your numerator, which is 17, and divide that guy by the denominator, which is 3. 3 goes into 17 5 times. 5 times 3 is 15. Subtract and get 2. So this is 5 with a remainder of 2. So to set up our mixed number, 5 will be the whole number part, right? That's your quotient from the division. 2 will be the numerator for the fraction part, right? That comes from the remainder. And then 3 will be the denominator for the fraction part, because again, we use the denominator from the improper fraction. So 17/3 is equal to 5 2/3. What about 23/9? Well, again, take 23 and divide that guy by 9. 9 goes into 23 twice. 2 times 9 is 18. Subtract here, borrow from the 2. 13 minus 8 is 5. So we get 2 with a remainder of 5. So now we can set up our mixed number. So the whole number part will be a 2, right? That's your quotient from the division. The numerator for the fraction part will be a 5, right? That comes from your remainder. And then the denominator part for the fraction in the mixed number is going to be a 9, right? Again, we just copy that from the denominator of the improper fraction. So 23/9 is equal to 2 5/9. Hello and welcome to Pre-Algebra Test Section 3 on mixed numbers and improper fractions. Okay, so we just want to convert each improper fraction into a mixed number. And we're going to start out with 51/2. So if we have an improper fraction and we want to convert it into a mixed number, the first thing we do is we divide the numerator by the denominator. So what is 51 divided by 2? 2 goes into 5 twice. 2 times 2 is 4. Subtract and get 1. Now I'm going to bring down this 1. 2 goes into 11 5 times. 5 times 2 is 10. Subtract and get 1. So this division would give us 25 with a remainder of 1. Now we're going to use this information to build our mixed number. So the whole number part of the mixed number comes from the quotient, which in this case is 25. The numerator for the fraction part of the mixed number comes from the remainder. So in this case, your remainder is 1. So that's going to be my numerator for the fraction part. And then the denominator for the fraction part of the mixed number is the same as the denominator from your improper fraction. So that's just going to be a 2. So 51/2 is the same thing as 25 1/2. What about 78/19? Again, just set up a long division. So we'd have 78, my numerator, divided by 19, my denominator. So how many times will 19 go into 78? Well, again, when we do long division and we don't have numbers that we're very familiar with, we kind of have to make some educated guesses. I'm going to think that 19 times 4 is going to do the trick for me. I know that 20 times 4 is 80. 19 times 4 should be 4 less than that, which means it's 76. So 19 will go into 78 4 times. 4 times 19, as I just said, is 76. Subtract and you get 2. So this is 4 with a remainder of 2. So let's build our mixed number now. So the whole number part is the 4, right? That's the quotient from the division. The numerator for the fraction part is a 2, right? That comes from the remainder. And then the 19, which in the improper fraction is your denominator, is going to be the denominator for the fraction part of the mixed number. So 78/19 is equal to 4 2/19. Okay, so let's take a look at 115/11. So we have 115, and we're going to divide that by 11. So 11 is not going to go into 1, but it can go into 11. 11 goes into 11 once. 1 times 11 is 11. Subtract and get 0. Bring down the 5 there. 11 goes into 5 0 times. 0 times 11 is 0. Subtract and get 5. So we would get 10 with a remainder of 5. So let's build our mixed number. So we know that the whole number part is going to be 10, right? That's the quotient from the division. The numerator for the fraction part is a 5, right? We get that from the remainder. And then the denominator for the fraction part, we steal that from the denominator of the improper fraction, so that's going to be an 11. So 115/11 is equal to 10 5/11. Hello and welcome to Pre-Algebra Test Section 4 on mixed numbers and improper fractions. So we want to convert each mixed number into an improper fraction. Okay, so we're going to begin with 18 1/3. And what we're going to do is we're going to take the denominator from the fraction part of the mixed number, which in this case is a 3, and we're going to multiply that guy by the whole number part of the mixed number, which is 18. Now once we've done that operation, we're going to add our numerator, so plus 1, and this is all over the denominator from the fraction part of the mixed number. So it's all going to be over 3. So what is 3 times 18? 3 times 18, or 18 times 3. 3 times 8 is 24. 3 times 1 is 3, plus 2 is 5. So that's 54. If I add 1 to that, I get 55. So this is 55 over 3. And that's it. It's just that simple. Let's take a look at 12 1/2. Again, I'm going to take the denominator from the fraction part of the mixed number, which is 2, and I'm going to multiply it by 12, the whole number part of the mixed number. When this is done, we add to it 1, which is the numerator from the fraction part of the mixed number. And then this is all going to be over a 2, right? That's the denominator from the fraction part of the mixed number. So 2 times 12, or 12 times 2 is 24. If you add 1 to that, you get 25, and this is over 2. So what we get is 12 1/2 is equal to 25 halves. All right, let's take a look at 14 3/5. Again, take the denominator from the fraction part of the mixed number, which is 5 in this case, multiply by the whole number part. So 5 times 14, and then we're going to add to that the numerator from the fraction part of the mixed number, so plus 3. And then put this over a 5, right, which is the denominator from the fraction part of the mixed number. So what's 5 times 14? So 14 times 5, 5 times 4 is 20. 5 times 1 is 5, plus 2 is 7. So that's 70. If I add 3 to that, I just get 73. And this is over 5. So 14 3/5 is equal to 73/5. Hello and welcome to Pre-Algebra Test Section 5 on mixed numbers and improper fractions. Okay, so we just want to convert each mixed number into an improper fraction. So we're going to start out with 7 11/13. So it's pretty easy to convert a mixed number to an improper fraction. All we really need to do is take the denominator from the fraction part of the mixed number, which in this case is 13, and multiply it by the whole number part. So we'd have 13 times 7. Now, once we've performed this operation, we're going to add 11, which is the numerator from the fraction part of the mixed number. Now, the denominator for this improper fraction that we're making comes from the denominator of the fraction part of the mixed number. So the denominator is just going to be 13. So let's crank this out. What is 13 times 7? 7 times 3 is 21. 7 times 1 is 7, plus 2 is 9. So this is 91, and I would add 11 to that. So 91 plus 11. 1 plus 1 is 2. 9 plus 1 is 10. So the numerator is going to be 102, and the denominator is going to be 13. So 7 11/13 is equal to 102/13. What about 21 8/9? Well, again, just take your denominator from the fraction part of the mixed number, which in this case is 9, and multiply it by the whole number part. So times 21. When we're done with this, we're going to add 8, which again is the numerator for the fraction part of the mixed number, and put this over 9, which is your denominator from the fraction part of the mixed number. So what is 21 times 9? 9 times 1 is 9. 9 times 2 is 18. So this is 189. Then we're adding 8. 9 plus 8 is 17. 1 plus 8 is 9. Bring down the 1. So this is 197 over a denominator of 9. So 21 8/9 is equal to 197 ninths. All right, lastly, we're going to look at 7 7/9. So again, we take our denominator from the fraction part of the mixed number, which in this case is a 9, multiply by the whole number part, which is a 7. When we're done, we add the numerator from the fraction part of the mixed number. So we're going to add 7 to that. And remember, our denominator is the same as the denominator from the fraction part of the mixed number. So we all know that 9 times 7 is 63, and 63 plus 7 is 70. So this would be 70 over 9, or we could say that 7 and 7/9 is equal to 70/9. Hello and welcome to Pre-Algebra Practice Set number 28. In this video, we're going to look at some additional practice problems for our lesson on finding the greatest common divisor. So we want to find the greatest common divisor for each group of numbers. We're going to start out with finding the greatest common divisor for 12 and 27. So before we kind of get started here, I want to just remind you that finding the greatest common divisor and finding the greatest common factor is the same thing. So if I asked you for the greatest common divisor of 12 and 27, I could have also said what is the greatest common factor of 12 and 27, and it would be the exact same thing. So we begin by finding the prime factorization for each number. So for 12, I could do 4 times 3, or I could do 6 times 2. Let's do that. 6 times 2. I'm going to circle 2 because it's prime, and then 6 is 3 times 2. And 3 and 2 are both prime, so I'm going to circle both of those. Then for 27, we begin with 9 times 3. 3 is prime, so we're going to circle that. Then 9 is 3 times 3. 3 is prime, so we're going to circle both of those. All right, so let's write the prime factorization for each number below. So 12 is 2 times 2 times 3. 27 is 3 times 3 times 3. So the next thing we're going to do is build a list. And that list is going to contain all the prime factors that are common to each prime factorization. So for example, when I look at the prime factorization of 12, I see a 2, a 2, and a 3. So looking at 27, I don't see any 2s, and I see 3 3s. Now, I just have 1 3 in the prime factorization of 12, so I can match that with 1 3 from the prime factorization of 27. So in my list, I will just have one number, and that's just one single 3. Again, so that you're not confused, I'm not putting any 2s in my list because there's no 2s in the prime factorization of 27. It's got to be common to everything. I only put one single 3 in my list because 12 has 1 3 in the prime factorization. I can't do anything with these other 2 3s in the prime factorization of 27 because they're not common to both, right? It's got to be common to both. So my list contains one single number, so in this case, it's going to be the answer. So the greatest common divisor of 12 and 27 is going to be 3. Now, in most cases, you have more than one number in your list. When that happens, you just multiply the numbers in your list together, and that would give you your greatest common divisor. In this case, we just have one number, so that is the greatest common divisor. And again, it's 3 in this case. Okay, let's look at finding the greatest common divisor for 945 and 840. So 945. And again, when you try to factor a number like this, use your divisibility rules. We don't work with 945 that often, but we can see it ends in a 5. So we know that it's at minimum divisible by 5. 5 goes into 9 once. 1 times 5 is 5. Subtract, you get 4. Bring down the 4. 5 goes into 44 8 times. 8 times 5 is 40. Subtract, you get 4. Bring down the 5. 5 goes into 45 9 times. 9 times 5 is 45. Subtract, and you would get 0. So 189 times 5 would give me 945. I know that 5 is a prime number, so I can circle and stop. What about 189? Just eyeballing it, 1 plus 8 is 9, 9 plus 9 is 18, so this number is divisible by 9. So it's divisible by 9, so we do 189 divided by 9. 9 goes in 18 twice. 2 times 9 is 18. Subtracting gets 0. Bring down the 9. 9 goes into 9 once. 1 times 9 is 9. Subtracting gets 0. So 21 times 9 is 189. Now neither number is prime. 9 is 3 times 3. 3 is prime, so we can circle both of these. And then 21 is 7 times 3. 7 and 3 are both prime, so we can circle those. So what I'm going to do is I'm going to take this prime factorization, I'm going to write it on the next page. So 945 is 3 times 3 times 3, or 3 cubed times 5 times 7. 945 is 3 times 3 times 3 times 5 times 7. All right, now let's find the prime factorization for 840. Now, this number ends in a 0, so I know that it's divisible by 10. So if I divide a number with a trailing 0 by 10, I just cut the 0 off. So 840 would be 84 times 10. Now 10 and 84, neither of those are prime. 10 is 5 times 2. 5 and 2 are both prime. 84, I know that ends in a 4, so it's an even number. It's at least divisible by 2. So in order to figure out if 84 is divisible by 4, I'd have to actually do the division. So 84 divided by 4. 4 goes in 8 twice. 2 times 4 is 8. Subtracting gets 0. Bring down the 4. 4 goes into 4 once. 1 times 4 is 4. Subtracting gets 0. So 84 is 21 times 4. Neither number is prime, so we continue. 4 is 2 times 2. 2 is prime, so we're going to circle both. 21 is 7 times 3. 7 and 3 are both prime, so we're going to circle both of those. So 840, we're going to write the prime factorization for this on the next page. So we have 2 times 2 times 2, or 2 cubed, times 3 times 5 times 7. So 840, 2 times 2 times 2, times 3 times 5 times 7. And when you start getting a lot of numbers here, it kind of helps to make a little table. So let's do that. So if I have 945 and I have 840, let's make a little table. So look for your smallest prime factor in any of these. In 840, it's 2, and I have 3 factors of that. So 2 times 2 times 2. And up here, I don't have any factors of 2, so I would just put spaces there. Now, the next smallest prime factor would be 3. So in 945, there's 3 of them. So I'd put 3 times 3 times 3. Here, there's just 1. So I'm going to put times 3, and then spaces there. And then the next largest prime factor is 5. So then times 5, down here to be times 5, and then times 7 times 7. So when you make a little table like this, you're just making it easy to see what's common to both, right? I can immediately tell that 2 is not common to both. I can tell that there's 1 3 that's going to be common to both, 1 5, and 1 7. These 3's here are not going to be common to both because there's nothing to match it with down here. So kind of a simple way to do it when you have some large numbers with a prime factorization that's a decent size. So the GCD, or the greatest common divisor, for 945 and 840, again, you would form a list, and the list has what's in common there. So it would be 3, 5, and 7, and you would just multiply these numbers together. So 3 times 5 times 7. 3 times 5 is 15. 15 times 7. 7 times 5 is 35. 7 times 1 is 7, plus 3 is 10. So this would be 105. So the greatest common divisor, or again, the greatest common factor of 945 and 840 is 105. All right, what about the greatest common divisor for 399 and 200? So 399. So 399, nothing jumps out at me right away. When I see numbers that end with a 9, I always try to see if they're divisible by 9. So 3 plus 9 is 12. 12 plus 9 is 21. 21 is not divisible by 9, but it is divisible by 3. So I know that 3 times something will give me 399. 3 goes into 3 once. 1 times 3 is 3. Subtracting gets 0. Bring down the 9. 3 goes into 9 3 times. 3 times 3 is 9. Subtracting gets 0. Bring down the 9. 3 goes into 9 3 times. 3 times 3 is 9. Subtracting gets 0. So 3 times 133 would give me 399. Now 3 is a prime number, so I can circle that and stop. 133, is that a prime number? Well, I don't really know. So what I can do is use my square root trick. Punch up square root of 133 in your calculator. You'll get about 11.5. So just go to the next highest whole number. So that would be 12. So I'm going to test all the prime numbers from 2 up through 12. So I'm going to test for 2, 3, 5, 7, and 11. So I know it's not divisible by 2, it's not even. 1 plus 3 is 4, 4 plus 3 is 7, not divisible by 3. Doesn't end in a 5 or 0, not divisible by 5. For 7, cut off the final digit of the number, so I'd have 13. Double that, 3 times 2 is 6, subtract it away. 13 minus 6 is 7. it is going to be divisible by 7. So let's divide this guy by 7. 7 goes into 13 once. 1 times 7 is 7. Subtracting gets 6. Bring down the 3. 7 goes into 63 9 times. 9 times 7 is 63. Subtracting gets 0. So 133 is 7 times 19. So we'll circle 7 and circle 19 because those are both prime numbers. And our prime factorization is going to be 3 times 7 times 19. So for 399, it's 3 times 7 times 19. All right, what about 200? 200 is easy because it has 2 trailing zeros. So 100 times 2 is 200. So let's start with that. 100 times 2. 2 is prime, so we can circle that. 100 I could do, let's say 25 times 4. 4 is 2 times 2. 2 is prime, so I can circle both of those. 25 is 5 times 5. 5 is prime, so I can circle both of those. So 2 cubed times 5 squared. So 200 is 2 times 2 times 2 times 5 times 5. Now we can go through and make a little chart like we did in the last one, but really it's not necessary because if you just kind of eyeball this, you see that there's nothing in common. This has a prime factor of 3, there's no 3 here. This has a prime factor of 7, there's no 7 here. This has a prime factor of 19, there's no 19 here. So really I've checked through everything. There's nothing else I can do. The greatest common divisor here, the greatest common divisor of 399 and 200 is going to be 1. So when there's no factors in common, the greatest common divisor is 1, because remember, I can take any number and divide it by 1 and get itself. So 1 is a divisor for everything. So when there's nothing in common, 1 is going to be the greatest common divisor or the greatest common factor. All right, what about one with 3 numbers involved? So we have 15, 75, and 60. So this one's pretty easy. So we have 15, that's 5 times 3. Circle 5, circle 3. 75, I could think of as 5 times 15. Circle 5. 15 is 5 times 3. 5 and 3 are both prime. And then 60 is 5 times 12. 5 is prime, circle that. 12 is 4 times 3. 3 is prime, circle that. 4 is 2 times 2. 2 is prime, we're going to circle both of those. So pretty easy to get the prime factorization for these 3 numbers. And now we just go through and say, okay, 15 is 5 times 3. 75 is 5 times 5 times 3. And then 60 is 5 times 3 times 2 times 2. So 5 times 3 times 2 times 2. So when we look at these numbers to build our list, okay, our list, we see that everything has a 5 in the prime factorization. Everything has a 3 in the prime factorization, and that's it. We really can't do anything else. So the list would have a 5 and a 3. So the greatest common divisor here for 15, 75, and 60 would be 5 times 3, which is 15. All right, for the last one, we have the greatest common divisor of 2,600, 650, and 1,300. So 2,600, we will begin by factoring this guy. It has 2 trailing zeros, so I know I can do 26 times 100. 26 is 13 times 2. 13 and 2 are each prime numbers. 100, I can do 25 times 4. 4 is 2 times 2. 25 is 5 times 5. And 5 and 2 are each prime numbers, so we're going to circle these guys. So the prime factorization for 2600, we're going to have 1, 2, 3 factors of 2, or 2 cubed, times 2 factors of 5, or 5 squared, times 13. So 2,600, let's write this guy as 2 times 2 times 2, times 5 times 5, times 13. Okay, what about 650? Well, it has 1 trailing 0, so I know it's divisible by 10. So let's do 65 times 10. 10 is 5 times 2. 5 and 2 are prime, so we can circle those. Now for 65, just use some mental math here. So most of you are going to know that 60 divided by 5 gives you 12, right? Meaning that 12 times 5 gives you 60. So knowing that, what would 13 times 5 be? Well, it would be 65. right? It would be 5 more than what you got here. So then 65 is 13 times 5. So now I know that 13 is prime, and I know that 5 is prime, so we can circle both of those. So 650 is going to be 2 times 5 squared times 13. What about 1300? 2 trailing zeros at the end, so I know it's divisible by 100. So I can do 13 times 100. 13 is prime, so I can circle that guy. 100 is 25 times 4, or let's go ahead and do 10 times 10. 10 is 5 times 2, and 5 and 2 are prime numbers, so we can circle all of these, and we're done. So the prime factorization here is 2 squared times 5 squared times 13. So for 1300, it's 2 times 2 times 5 times 5 times 13. All right, so when you have a lot of numbers involved here, sometimes it'll help you to make a little table. Now you don't have to do this. You can kind of just do it with your pen and paper like you normally do, but a table will sometimes be helpful for you. So 2600, 650, and 1300. And basically what you want to do is just try to line the common factors on top of each other. So for example, with 2600, the smallest factor is a 2. So I'm going to start out by putting 2 times 2 times 2. Now I go down to the next number and I look for 2's. So I just have one factor. And then I'm just going to arrow out the rest of this because I'm not going to have 3 factors of 2. I'm not going to have 2 factors of 2. I'm only going to have one factor of 2 that's common to both of these numbers. Now even if I have more than one factor of 2 in 1300 as I do, I've already boxed it out telling me that it's not going to be common to everything. And you don't really even need a box. You could just put a line or something. It doesn't really matter. It's just showing that it's not common to everything. So for 1300, I have 2 factors of 2. And then I'm going to put a little line there. And you can kind of cut that off. Now I know that I'm going to have 1, 2 that's going to be common to everything, right? 1, 2, and only 1, 2. Now, moving to the next smallest factor, that's going to be a 5. So in 2600, I have 2 of those guys. In 650, I have 2 of those guys. And in 1300, I have 2 of those guys. Then I have 13. I have one factor in every number. So really, all these are common to everything. So when I build my list is going to contain what's common to everything. And it's what's highlighted here. It's got 1, 2. It's got 2 5s. And it's got 1 13 in it. And to find the greatest common divisor, for 2600, 650, and 1300, really what I'm doing is I'm just multiplying the numbers on the list together. So 2 times 5 times 5 times 13. 2 times 5 is 10. 10 times 5 is 50. So then I have 50 times 13. So 3 times 0 is 0. 3 times 5 is 15. 1 times 50 is 50. Bring down the 0. 5 plus 0 is 5. 1 plus 5 is 6. So we're going to end up with 650 as our answer. Hello and welcome to Pre-Algebra Test Section 1 on finding the greatest common divisor. So we just want to find the greatest common divisor for each group of numbers. We're going to start out with finding the greatest common divisor for 26 and 65. So the first step is always just to factor the numbers. So for 26, it's just 13 times 2. 13 times 2. Each number here is prime, so we can circle and stop. For 65, I did this in another video, so I already know that it's 13 times 5. But again, a little mental trick to help you with that. If you know that 12 times 5 is 60, well then 13 times 5 would be 5 more than that, so 65. So we're going to circle 13 and 5 because those are both prime. So now that we've found the prime factorization for each number, let's just write it down here. So we have 26 is equal to 13 times 2. 65 is equal to 13 times 5. Now generally we'll make a list, and that list will contain all the numbers that are common to all the prime factorizations. Here we just have one single number, 13, that's common to both prime factorizations. So our list would just contain one number, and that number would be 13. Normally, when you have more than one number, to find the greatest common divisor, you find the product of all those numbers on your list. But since we just have one number here, so your greatest common divisor for 26 and 65 will just be this number 13, because that's the only number that's common to both prime factorizations. Okay, we're going to take a look at one more. We're going to find the greatest common divisor for 175. So we're going to factor each. So 100 I can do 10 times 10. 10 is 5 times 2. So we're going to circle 5 and 2 because those are prime. 75 I can think of as what? 5 times 15. 5 is prime. 15 is 5 times 3. 5 is prime. 3 is prime. So let's write this down here. We have 100 is equal to 2 times 2 times 5 times 5. We have 75 is equal to 3 times 5 times 5. So when we make our little list, again, we're looking for what's common to both prime factorizations. 2 is not common to both. 3 is not common to both. Just 5 is. Each prime factorization has 2 5s in it, so our list would contain 2 5s. So the greatest common divisor for the numbers 100 and then 75 would be 5 times 5, which is 25. Again, when you have more than one number on your list, you just find the product of all the numbers on the list. In this case, we have 2 5s. 5 times 5 gives us 25, so that's our answer. Hello and welcome to Pre-Algebra Test Section 2 on finding the greatest common divisor. So we want to just find the greatest common divisor for each group of numbers. We're starting out with the greatest common divisor of 87 and 406. So these are two numbers that we really don't work with that often. But basically, we want to just begin by finding the prime factorization for each number. So for 87, it's an odd number, so I know it's not divisible by 2. I can look and see that 8 plus 7 is 15. It's going to be divisible by 3. So let's start with that. What is 87 divided by 3? 3 goes into 8 twice. 2 times 3 is 6. Subtracting, you get 2. Bring down the 7. 3 goes into 27 9 times. 9 times 3 is 27. Subtracting gets 0. So 87 is 3 times 29. Now 3 is a prime number. A lot of you probably don't know at this point that 29 is a prime number, but it is. Again, use your square root trick that I taught you a few lessons ago. Square root of 29 on a calculator will give you about 5.38. If you go to the next highest whole number, that would be 6. 6 is not a prime number, so you don't even need to worry about it. Really, you would just need to test to see if 29 is divisible by 2, 3, and 5 to see if it's a prime number. It's not even, so it's not divisible by 2. 2 plus 9 is 11, not divisible by 3. Last digit is not a 0 or 5, so it's not divisible by 5. So it is a prime number. So 87, let me just write this down here. 87 is 3 times 29. What about 406? 406. Well, this one's even, so I know it's at least divisible by 2. It's not divisible by 4 because the final two digits form the number 6. 6 is not divisible by 4. 4 plus 6 is 10. It's not divisible by 3. So let's just try 406 divided by 2 and see what we get. 2 goes into 4 twice. 2 times 2 is 4. Subtracting gets 0. You'd bring down a 0. 2 goes into 0 0 times. 0 times 2 is 0. Subtract and you get 0. Bring down the 6. 2 goes into 6 3 times. 3 times 2 is 6. Subtracting you get 0. So 203 times 2. 203 times 2. Now I know 2 is a prime number, so I can circle that and stop. What about 203? So I don't know if this is prime or not, so I'd have to use my square root trick. So punch up square root of 203 on a calculator, you get about 14.24. So I'm going to test all the prime numbers from 2 up to and including 15, right? The next highest whole number. So that would give me 2, 3, 5, 7, 11, and 13 that I need to test. Right? 14 is not prime and neither is 15. So it's not divisible by 2 because it's not an even number. It's not divisible by 3. We just checked that. 2 plus 3 is 5. 5 is not divisible by 3. Not divisible by 5. It doesn't end in a 0 or 5. What about 7? So 203. Cut off the 3 and double it. 3 times 2 is 6. So if I cut off the 3 and double it, I get a 6. Subtract that away, I get 14. 14 is divisible by 7, so that means this number is divisible by 7. So what is 203 divided by 7? 7 goes into 20 twice. 2 times 7 is 14. Subtracting gets 6. Bring down the 3. 7 goes into 63 9 times. 9 times 7 is 63. Subtracting gets 0. So 29 times 7 is 203. Now 29 is prime, and so is 7. So the prime factorization for 406 is going to be 2 times 7 times 29. Now generally what we do in the next step is we make a list that contains all the numbers that are common to all the prime factorizations. Here we just have 2 prime factorizations to look at, and we only have one single number that's common to both, and that's that number 29. So generally speaking, we'll have more than one number, and to find our greatest common divisor, we'll find the product of the numbers on the list. But in this case, since we just have one number, it's just that number. So the greatest common divisor for 87 and then 406 is going to be 29, right? Just the number that's in common to both. Let's take a look at another one. What about the greatest common divisor for 1085 and 117? So for 1085, it ends in a 5, so I can start there. So 1085 divided by 5. 5 goes into 10 twice. 2 times 5 is 10. Subtracting, you get 0. Bring down the 8. 5 goes into 8 once. 1 times 5 is 5. Subtracting, you get 3. Bring down the 5. 5 goes into 35 7 times. 7 times 5 is 35. Subtracting, you get 0. So 217 times 5. 5 is prime, so we can circle that and stop. What about 217? Well, nothing jumps out at me, so take the square root of the number. You get about 14.73. So I need to test 2, 3, 5, 7, 11, and 13. Right? 14 and 15 are not prime numbers, so I don't need to worry about those. So right away I can cross out 2. It's not an even number. 2 plus 1 is 3. 3 plus 7 is 10, not divisible by 3. Not a 0 or a 5 for the final digit, so it's not divisible by 5. Let's think about 7. So 217, I would cut off the 7, and I would double it. So I'd take 21, that'd be my new number. 7 doubled is 14. 21 minus 14 is 7. 7 is divisible by 7. So 217 will be divisible by 7. 7 goes into 21 3 times. 3 times 7 is 21. Subtracting gets 0. Bring down the 7. 7 goes into 7 once. 1 times 7 is 7. Subtracting gets 0. So this is 31 times 7. 7 is prime, and so is 31. So 1085, we have 5 times 7 times 31. 1085, 5 times 7 times 31. Okay, let's check out 117. So what I normally do before I start thinking about is the number prime or not, I just go through the first few numbers to see if it's divisible. And I check 2. It's not an even number, so that's out right away. Then I think about 3. 1 plus 1 is 2. 2 plus 7 is 9. 9 divided by 3 is 3, no remainder, so I know it's divisible by 3. So 117 divided by 3. 3 goes into 11 3 times. 3 times 3 is 9. Subtracting, get 2. Bring down the 7. 3 goes into 27 9 times. 9 times 3 is 27. Subtracting, get 0. So 3 times 39 produces 117. Now 3 is prime, but 39 is not. 39 is 3 times 13. 3 is prime, and so is 13. So 117 is 3 times 3 times 13. 117 is 3 times 3 times 13. So on my list, remember, I'm trying to put things in that are common to both prime factorizations. Well, what happens is when we look through the prime factorizations, nothing's in common. This has a 5, this doesn't. This has a 7, this doesn't. This has a 31, this doesn't. This has a 3, this doesn't. This has a second 3, this doesn't. This has a 13, this doesn't. So nothing is in common. So my list is pretty much just blank. Right? I'm going to put a sad face. That's my list. So what happens is for your greatest common divisor for these two numbers, 1085 and 117, it's just going to be 1. Remember that 1 is going to be a factor or a divisor for any number, right? If I take a number and I divide it by 1, I just get the number back. So when this happens and you have no numbers that are common to both prime factorizations, your greatest common divisor is 1. Hello and welcome to Pre-Algebra Test Section 3 on finding the greatest common divisor. So we're going to find the greatest common divisor for each group of numbers. We just have one problem here, and we're going to work on the greatest common divisor of 805, 322, and 4025. So the first thing you're going to do is find the prime factorization for each number. So we'll start with 805. Now it ends with a 5, so I know it's divisible by 5. So 805 divided by 5. 5 goes in 8 once. 1 times 5 is 5. Subtract, you get 3. And bring down the 0. 5 goes into 36 times. 6 times 5 is 30. Subtract and get 0. Bring down the 5. 5 goes into 5 once. 1 times 5 is 5. Subtract and get 0. So 161 times 5 would give me 805. Now I know that 5 is a prime number. I don't know about 161. I don't work with it that often. Usually I'll look at the first few numbers. It's not divisible by 2. 1 plus 6 is 7. 7 plus 1 is 8. Not divisible by 3. 61 is not divisible by 4. It's not divisible by 5. So at that point, I pull out my calculator and I see, what's the square root of 161? Well, it's about 12.68. So I would test all the prime numbers up through and including 13. So that means I'm looking at 2, 3, 5, 7, 11, and 13. Now I already crossed these out. I need to look at 7. So for 7, I remove the last digit of the number. So take the 1 off, double it. 1 times 2 is 2. Subtract it away. I get 14. 14 is divisible by 7. So 161 is going to be divisible by 7. So it's not a prime number. 7 will go into 16 twice. 2 times 7 is 14. Subtract and get 2. Bring down the 1. 7 goes into 21 3 times. 3 times 7 is 21. Subtract and get 0. So 7 times 23 is 161. So we know that 7 is prime and 23 is prime. So now we're done. The prime factorization of 805 is 5 times 7 times 23. So 805 is 5 times 7 times 23. Okay, the next number is 322. So that's an even number, so I know it's at least divisible by 2. So let's start by dividing 322 by 2. 2 goes into 3 once. 1 times 2 is 2. Subtract and get 1. Let's bring down this 2 here. 2 goes into 12 6 times. 6 times 2 is 12. Subtract and get 0. Bring down the 2. 2 goes into 2 once. 1 times 2 is 2. Subtract and get 0. So 2 times 161 is 322. Now, we just looked at 161 and we found that it was 23 times 7. So now everything is prime here. 2 is prime, 23 is prime, and 7 is prime. So for 322, we have 2 times 7 times 23. All right, lastly, we have 4025. So the number ends in a 5. So I know it's divisible by 5. So 4025 divided by 5. 5 goes into 48 times. 8 times 5 is 40. Subtract, you get 0. Bring down the 2. 5 is not going to go into 2, so I put a 0. 0 times 5 is 0. Subtract and get 2. Bring down the 5. 5 goes into 25 5 times. 5 times 5 is 25. Subtract and get 0. So 805 times 5 gives me 4025. So 5 is prime. 805 is not. It ends in a 5, so it's divisible by 5. So 805 divided by 5. 5 goes into 8 once. 1 times 5 is 5. Subtract and get 3. Bring down the 0. 5 goes into 36 times. 6 times 5 is 30. Subtract and get 0. Bring down the 5. 5 goes into 5 once. 1 times 5 is 5. Subtract and get 0. So here we get our number again, 161. So we know 5 is prime. And 161, we know already that that is 23 times 7. So for 4025, we're going to have the prime factorization as 5 times 5 times 7 times 23. So now that we have all the prime factorizations, we just want to look and see what's common to everything. So I have a 5 here, but no 5 here, so 5 can't be in the list. It's got to be common to everything. I have a 7 here, a 7 here, and a 7 here. So 7's going to go on the list. I have a 23, a 23, and a 23, so that's going in the list. And I have this 2 over here, but it's not in any other prime factorization, so that's not going in. So the only thing that's going in the list is 7 and then 23. That's it. So for my greatest common divisor, all I do is I form the product of the numbers in the list. Meaning I'm just going to multiply 7 times 23, and we already know that's 161, and that's going to be my greatest common divisor, right? It's just the product of the numbers that are common to all the prime factorizations. Hello and welcome to Pre-Algebra Test Section 4 on finding the greatest common divisor. Okay, so we just want to find the greatest common divisor for each group of numbers, and we're looking at one problem here. We want to find the greatest common divisor for 1,620, 300, 1,500, and 3,900. So the first thing I'm going to do is find the prime factorization for each number involved. So I'm going to start out with 1,620, and it has a trailing 0, so I know it's divisible by 10. So I can do 162 times 10. 10 is 5 times 2. 5 and 2 are each prime numbers. So I'm going to circle these and stop. 162 is even, so it's at least divisible by 2. What is 162 divided by 2? 2 goes into 16 8 times. 8 times 2 is 16. Subtract, that will give you 0. Bring down the 2. 2 goes into 2 once. 1 times 2 is 2. Subtract and get 0. So 2 times 81. So 2 is prime. 81 is 9 times 9. And 9 is 3 times 3. 3 is prime, so we're going to circle those guys. So my prime factorization is 2 times 2, or 2 squared, times 3 times 3, times 3 times 3, or 3 to the 4th power, times 5. All right, let's take a look at 300. So it ends with 2 trailing zeros. So I know I could do 3 times 100. 3 is prime. Then for 100, I could do 10 times 10. 10 is 5 times 2. 5 and 2 are prime numbers, so we can circle those. And so we have our prime factorization. We have 2 times 2, or 2 squared, times 3, times 5, or 5 squared. So 300. So 2 times 2 times 3. And I'm going to try to write it to where it lines up. So I'm going to skip some spaces over here and put times 5 times 5. Okay, let's look at 1,500 now. So it's got 2 trailing zeros, so I can do 15 times 100. 15 is 5 times 3. 5 and 3 are prime numbers. 100, I can do 10 times 10. I know 10 is 5 times 2. 5 and 2 are prime numbers. So the prime factorization here is 2 times 2, or 2 squared, times 3, times 5 times 5 times 5, or 5 cubed. So 1,500 is equal to, I've got 2 factors of 2, times 1 factor of 3, times, and then I've got 3 factors of 5. And I'll remove this multiplication symbol here just to keep this consistent. And again, I'm just leaving this space blank so we can see what we have in common. All right, last one we're going to do is 3,900. So 2 trailing zeros, I know I can do 39 times 100. 100 is 10 times 10. 10 is 5 times 2. 5 and 2 are prime. 39 is 3 times 13. 13 and 3 are both prime. So the prime factorization here is 2 squared times 3 times 5 squared times 13. So 1,300, again, 2 squared, or 2 times 2, times 3, times 5, times 5, and then I have times 13. So the next thing we're looking for is to make a list of what's common to all the prime factorizations. So I have 1, 2 that's common to everything. then a second 2 that's common to everything. So I'm going to put 2 2s in there. I have one 3 that's common to everything. But look here, I have a 3, another 3, and another 3 that's in the prime factorization of 1620 that's not matched anywhere else. So because it's not common to everything, it doesn't go in there. Even if it was common to 3 of them, but not the 4th, it doesn't go in there. It's got to be common to everything. Let me go ahead and put this 3. The next number that would go in would be this 5 here. That's common to everything. So this 5 goes in. And notice how a second 5 is common to everything except for 1620. So that means it doesn't go in, right? It's not common to everything. And then we look down here, we have a third factor of 5 and 1500, and we have this factor of 13 and 1300. Again, if it's not common to everything, it doesn't go in. So we have 2, another 2, a 3, and then a 5. These are the numbers that were common to all the prime factorizations, so that's what goes on our list. So then for my greatest common divisor, for 1620, 300, 1500, and then 1300, all I'm going to do is find the product of the numbers on the list. So 2 times 2 times 3 times 5. 2 times 2 is 4, 4 times 3 is 12, 12 times 5 is 60. Hello and welcome to Pre-Algebra Test Section 5 on finding the greatest common divisor. So we want to find the greatest common divisor for each group of numbers. And we're just going to look at one problem here. So we want to find the greatest common divisor for 2,400, 3,150, and 6,300. So our first step is to find the prime factorization for each number. So we'll start out with 2,400. It ends with 2 trailing zeros, so it's divisible by 100. So 24 times 100. 24 is 8 times 3. You could do that. 3 is prime. 8 is 4 times 2. 2 is prime. 4 is 2 times 2. 2 is prime. And we're going to circle both of those. Now let's look at 100. 100, let's do 25 times 4. 4, let's do 2 times 2. And 2 is prime, so we're going to circle those. 25 is 5 times 5. 5 is prime, so we're going to circle those. So 2,400 is going to be 2 times 2 times 2 times 2 times 2, or 2 to the 5th power, times 3 times 5, or 5 squared. So 2,400 is equal to 2 times 2 times 2 times 2 times 2. So 1, 2, 3, 4, 5 factors of 2 times 3 times 5 times 5. All right, next we're looking at 3,150. So that ends with a 0. So that means it's divisible by 10. So I can do 315 times 10. 10 is 5 times 2. 5 and 2 are prime numbers. What about 315? Let's see that number too often. Is it prime? No, I know that it isn't because it ends in a 5. So I can do 315 divided by 5. 5 goes into 31 6 times. 6 times 5 is 30. Subtract and get 1. Bring down the 5. 5 goes into 15 3 times. 3 times 5 is 15. Subtract and get 0. So 63 times 5 gives me 315. Now I know that 5 is prime, so I can circle that and stop. What about 63? Well, I know that's 9 times 7. 9 times 7. 7 is prime. 9 is 3 times 3. 3 is prime. We're going to circle both of those. So the prime factorization here is going to be 2 times 3 times 3, or 3 squared, times 5 times 5, or 5 squared, times 7. And then usually I try to write the common factors on top, but this one's going to be pretty easy. I'm just going to write 2 times 3 times 3 times 5 times 5 times 7. Okay, the last one we're going to look at is 6,300. It ends with 2 trailing zeros, so we can do 63 times 100. 100 we can do 10 times 10. 10 is 5 times 2. Okay, we're going to circle the 5 and the 2. The 5 and the 2, those are prime. 63 we know is 9 times 7. 7 is prime. 9 is 3 times 3. Circle the 3's. And we have our prime factorization. So we have 2 times 2, or 2 squared, times 3 times 3, or 3 squared, times 5 times 5, or 5 squared, times 7. So once we've found all the prime factorizations, we make a list. And in this list, we look for all the numbers that are common to every prime factorization. So if it's not common to every prime factorization, it does not go in the list. So when I look here, let's start with 2. So I've got 2, 2, and 2. So I've got 1, 2 that can go on my list. What about a second 2? Well, no. Although there's 1, 2, 3, 4 more 2's in this prime factorization, there's no more 2's in this one, so I can't put it in the list, right? There's 1 more 2 in this one, but it doesn't matter. It's got to be common to everything, and what's common to everything is 1, 2. When I start looking here, and I can kind of just temporarily line out these 2's just to get them out of my way. The next thing I think about is 3. Now I have a 3 here, here, and here. So 1, 3 will be common to everything. So I'll put a 3 in the list. But again, I have more 3's in other factorizations, but I only have 1 here, so only 1 goes in the list. So I can kind of line these out. I'm not going to think about them anymore. And then what about 5? Well, I have 1, 2 factors of 5 here, 1, 2 factors of 5 here, and 1, 2 factors of 5 here. So in each prime factorization, there are 2 5's, so I can put 2 5's in my list. And this prime factorization doesn't have a 7, although these 2 do. So that doesn't go on the list, and our list is complete. So our list has a 2, a 3, and then 2 5's. What do we do with the list? Well, we multiply the numbers together to get our greatest common divisor. So the greatest common divisor for 2,400, 3,150, and 6,300 is equal to, again, multiply these numbers together. 2 times 3 times 5 times 5. 2 times 3 is 6. 6 times 5 is 30. 30 times 5 is 150. Hello and welcome to Pre-Algebra Practice Set number 29. In this video, we're going to look at some additional practice problems for our lesson on simplifying fractions. So for the problems in this video, we want to reduce each fraction to its lowest terms. And again, if I ask you to simplify a fraction, or if I ask you to reduce a fraction to its lowest terms, I'm asking for the exact same thing. So for our first problem, we have 23 over 46. And this is kind of a problem that students will struggle with. Here's why. When we start this problem out, we factor the numerator and denominator completely. So 23 doesn't factor, it's a prime number. 46 is 23 times 2. Our next step is to cancel common factors between the numerator and denominator. So we cancel this 23 with this 23. Now at this point, a lot of students get confused and they'll say, okay, I don't have anything up here, so I'll put a 0. And then in my denominator, I have a 2. 0 over 2 is 0. That's the wrong answer. And here's why. 23 over 23 is equal to 1. 23 over 23 is equal to 1. And really, I could write this as 1 over 1. So I can replace this 23 up in the top with a 1. I can replace this 23 in the bottom, and then I can put times 2 like this. And then it's crystal clear that what I have is 1 over 2, or 1/2. Another thing I can do, if I have something that completely cancels like this, I can just start out by saying 23 times 1. Remember, 23 times 1 is just 23. So mathematically, this is the same thing as 23 over there. Now when I cancel 23 with 23, it's crystal clear that I have 1/2, right? A 1 in the numerator over a 2 in the denominator. And then kind of an alternative way to think about this is, if I just divide the numerator and denominator by the greatest common divisor, right? The greatest common divisor, which we learned about in our last lesson. So the greatest common divisor for 23 and 46 is 23. If I divide 23 by 23, I get 1, right? It would not be 0. If I divide 46 by 23, I'd get 2. So those are different ways to kind of see that you would end up with 1/2. In the future, if your numerator cancels completely, it's going to be 1. If your denominator cancels completely, it's going to be 1. So if I flip this and had 46 over 23, now I'd have 23 times 2 in the numerator and 23 in the denominator. So 23 here would cancel with 23 here. And the denominator has canceled completely, so I know just to write a 1. And then the numerator is a 2. 2 over 1. I can leave it like that or just write it as 2. This is essentially the same problem as 46 divided by 23, and 46 divided by 23 is 2. What about 2 over 13? Well, this is another unique situation. 2 is a prime number. 13 is a prime number. So we don't really have anything we can cancel between numerator and denominator. The only common factor we have here is 1, right? I could write 2 times 1 over 13 times 1. You know, if you wanted to, you could cancel the common factor of 1, but you still have 2 over 13, right? So when you have a situation like this, where essentially the greatest common divisor, or remember the same thing as the greatest common factor, right? These are the same. When the greatest common divisor or the greatest common factor is 1, you're not going to be able to simplify the fraction, right? So the result is just going to stay the same. It's just going to be 2/13. What about 81 over 324? Well, 81, I know I can do 9 times 9, and 9 is 3 times 3. So 4 factors of 3. Then 324, we're going to divide this by 4. All right, and the reason I'm going to divide this by 4 to start is I see that 24, the final 2 digits of that number, would be divisible by 4. Right? 24 divided by 4 is 6, no remainder. So I know that 324 is divisible by 4. 4 goes into 32 8 times. 8 times 4 is 32. Subtract and get 0, bring down the 4. 4 goes into 4 once. 1 times 4 is 4. Subtract and get 0. So I don't need to make a factor tree here because I know what the prime factorization of 81 is. I just did it. It's 4 factors of 3. And then 4 is just 2 times 2. But essentially, 324 is what? It's just 81 times 4. So 81 over 81 is just 1. So I'm canceling 4 factors of 3, or 81, from the numerator with 4 factors of 3, or 81, from the denominator. And all I'm going to be left with is 2 times 2 in the denominator, or 4. And in the numerator, remember, if everything is canceled, I'm going to write a 1. I'm not going to write a 0. Right? So this is going to be 1/4. And again, just think about the greatest common divisor. The greatest common divisor, or the greatest common factor, of 81 and 324 is going to be 81. So if I divide 81 by 81, I get 1. If I divide 324 by 81, I get 4. What about negative 96 over 40? So again, I have a negative here, so I'm just going to write negative 1 times the prime factorization of 96. So for 96, I could do 32 times 3. 3 is prime. 32, I can do 4 times 8. 4 is 2 times 2. And 8 is 4 times 2. 2 is prime. And 4 is 2 times 2. And at this point, a lot of you will know that 32 is 5 factors of 2. If you don't need to make a factor tree, just skip it. Right? Anything that saves you time. Just make sure that you know it and you don't get the wrong answer. The last thing you want to do is have a wrong answer on a test because you made a simple mistake. So we have 1, 2, 3, 4, 5 factors of 2, 1 factor of 3. Okay, this is over. All right, what about 40? The number 40. Well, I know it's 4 times 10. 10 is 5 times 2. 4 is 2 times 2. So we'd have 2 times 2 times 2 times 5. So 3 factors of 2 times 5. So now I'm looking to cancel common factors between the numerator and the denominator. So I'm going to end up canceling 3 factors of 2 in the numerator with 3 factors of 2 in the denominator. Essentially, I'm canceling a common factor of 8 between both. So what's left in the numerator? 2 times 2 is 4. 4 times 3 is 12. Then times negative 1 is negative 12. And then over 5. So we end up with negative 12 fifths. And again, to kind of speed this up, if you know your greatest common factor or your greatest common divisor for the two numbers, if you know that that's 8, you can divide each number, right, the numerator and the denominator, by 8 and get to this result quicker. What about 34 over negative 136? So 34 I know is 17 times 2. What about negative 136? Well, I'm going to put negative 1 times, and then what's 136? 36 is divisible by 4, so I know 136 is. 4 goes into 13 3 times. 3 times 4 is 12. Subtract and get 1, bring down the 6. 4 goes into 16 4 times. 4 times 4 is 16. Subtract and get 0. So 4 times 34. 4 times 34. So do we need to make a factor tree? Well, 34 we just did. It's 17 times 2. And we know 4 is 2 times 2. So no, I don't need a factor tree. Now I can cancel this 17 with this 17, and this 2 with this 2. And again, if I've canceled my numerator completely, I'm going to put a 1. Right? I'm not going to put a 0. Please don't make that mistake. In the denominator, I have negative 1 times 2 times 2. 2 times 2 is 4. 4 times negative 1 is negative 4. Now, when we have a numerator that's positive and a denominator that's negative, we just write it as negative 1/4 like that. It doesn't really matter. You can keep it this way, but it's all going to be the same. If I have a negative in the denominator, or if I had a negative in the numerator, but not in the denominator, negative divided by positive or positive divided by negative is negative. So in the end, it's just negative 1/4. What about 32 over 72? So 32 I know is 5 factors of 2, right? We just did that earlier. So 1, 2, 3, 4, 5 factors of 2. 72 I know is 8 times 9. 8 is 3 factors of 2. 9 is 2 factors of 3. So now I can cancel 3 factors of 2 in the numerator with 3 factors of 2 in the denominator. Essentially, I'm removing a factor of 8 between the numerator and denominator. And so I have 2 times 2 or 4 in the numerator over 3 times 3 or 9 in the denominator. So we get 4/9 as our answer. And again, if you recognize that the greatest common divisor or the greatest common factor for 32 and 72 is 8, you can just divide them and get that quicker, right? So 32 divided by 8 would be 4, and I would write that down. 72 divided by 8 is 9, and I would write that down. And I would have my simplified fraction in a much quicker manner than going through and factoring and then canceling and whatnot. What about 24 over negative 9? So let's use a little shortcut here. I know that the greatest common divisor of 24 and 9, forget about the negative part, is going to be 3. So the greatest common divisor of 24 and 9 is 3. So 24 divided by 3 is 8. Negative 9 divided by 3 is negative 3. So you'd end up with 8 over negative 3, or you could write this as negative 8 over 3, or you could write this as negative 8/3. Again, when you have a positive divided by a negative, or a negative divided by a positive, the number is just negative. Now again, if we had done this the slower way, factor 24, it's 8 times 3. So 2 times 2 times 2 times 3. Negative 9, we'd write negative 1 times 3 times 3. And then we'd go through and cancel this factor of 3 with this factor of 3. And we end up with 2 times 2 times 2 or 8 over negative 1 times 3 or negative 3. Again, you get the same answer either way. All right, what about 10 over 28? So 10 over 28. I know that 10 is 5 times 2. So knowing that 28 is not divisible by 5, the greatest common divisor is going to be 2. So I could stop at this point and say that, okay, I'm going to divide 10 by 2 and get 5. I'm going to divide 28 by 2 and get 14. That's kind of a quicker way to do it, right? The greatest common divisor between 10 and 28 is going to be 2. Again, divide 10 by the greatest common divisor of 2, get 5. Divide 28 by the greatest common divisor, which is 2, and get 14. Or, again, the slower way, factor 10, that's 5 times 2. Factor 28, that's going to be 4 times 7. So 2 times 2 times 7. Cancel the 2 between the numerator and denominator. And you end up with 5 over 2 times 7 or 14. So however you do it, 5/14 is going to be your answer. Okay, for the last problem, we have negative 156 over 78. So I'm going to write negative 1 times, and then what's the prime factorization for 156? So 156, well, 56 is divisible by 4, so I know 156 is. 4 goes into 15 3 times. 3 times 4 is 12. Subtracting, get 3. Bring down the 6. 4 goes into 36 9 times. 9 times 4 is 36. Subtracting, get 0. So 39 times 4. 4 is 2 times 2. 2 is prime. 39 is 13 times 3. 13 and 3 are both prime numbers. So I'm going to write negative 1 times 13 times 3 times 2 times 2. Now what about 78? What about 78? I know it's divisible by 2, so let's start there. 2 goes into 7 3 times. 3 times 2 is 6. Subtracting get 1, bring down the 8. 2 goes into 18 9 times. 9 times 2 is 18. Subtracting get 0. So 39 times 2. So we know that 39 is 13 times 3. 13 times 3, and then times 2. So now we're going to cancel this 13 with this 13, this 3 with this 3, and this 2 with this 2. So the denominator canceled completely. So we're going to write it as a 1. And then for the numerator, we have negative 1 times 2. That's negative 2. So negative 2 over 1, anything over 1 is just itself. So we just write the answer as negative 2. And again, if you would have realized that the greatest common divisor between 156 and 78 was 78, you could have saved yourself a little bit of time. You just said, okay, what is negative 156 divided by 78? Okay, that's negative 2. Then what is 78 divided by 78? Well, that's 1. So I'd have negative 2 over 1, or just negative 2 as my answer. Hello and welcome to Pre-Algebra Test Section 1 on simplifying fractions. So we just want to reduce each fraction to its lowest terms. And we're going to start out with 39 over 45. So what we're going to do is factor the numerator and denominator completely, and then cancel common factors between the numerator and denominator. So 39, I know, is 13 times 3. For 45, I know it's 15 times 3. And 15 I know is 5 times 3. So basically I would have 5 times 3 times 3. Right? 5 times 3 is 15. 15 times 3 is 45. Now that I've factored my numerator and denominator completely, I'm going to cancel common factors between the numerator and denominator. And we're only going to be able to cancel one factor of 3 between the numerator and denominator. So our numerator will be 13. Right? That's all that's left. And our denominator will be 5 times 3, or 15. So 39 over 45 is the same as, or is equal to, 13 over 15, or 13/15. What about 32 over 144? So 32, we should know at this point is 5 factors of 2. So 2 times 2 times 2 times 2 times 2. What about 144? Well, I know it's 12 times 12, and I know 12 is 4 times 3. Think about 4 times 3 times 4 times 3. So 4 is 2 times 2. So 2 times 2 times 3 times 2 times 2 times 3. So what can we cancel here? This factor 2 with this factor 2, this factor 2 with this factor 2, this factor 2 with this factor 2, this factor 2 with this factor of 2. So in the numerator, I just have a 2 left. In the denominator, we have 3 times 3, or 9. So we end up with 2/9 as our answer. So the next one's pretty easy. We have 105 over negative 105. So recall that anytime you have a non-zero number over itself, it's just 1. Here we have a non-zero number, 105, over the negative of itself. So 105 over negative 105, when you have a non-zero number over the negative of itself, the result is negative 1. And to see this, let's just write this as 105 over negative 1 times 105. And then cancel 105 with 105. Remember, if you cancel out your numerator completely, you put a 1 there. So this will become 1 over negative 1. And 1 divided by negative 1 is negative 1. Hello and welcome to Pre-Algebra Test Section 2 on simplifying fractions. All right, so we just want to reduce each fraction to its lowest terms. And we're going to look at 77 over 126 to start. So the first thing we're going to do is factor the numerator and denominator completely. So 77 I know is 7 times 11. What about 126? Well, I know that's divisible by 2 because it's an even number. So let's just start with that. 2 goes into 12 6 times. 6 times 2 is 12. Subtract and get 0. Bring down the 6. 2 goes into 6 3 times. 3 times 2 is 6. Subtract and get 0. So 63 times 2. 63 times 2. So I know 63 is 7 times 9. So 7 times 9 is 3 times 3. And then times 2. Now let's look for common factors between the numerator and denominator that we can cancel. We can cancel this 7 with this 7 and nothing else. So my numerator will be 11. My denominator will be 3 times 3 or 9 times 2, which is 18. So we end up with 11/18 as our answer. All right, let's look at negative 361 over 152. So when we have a negative number involved, we'll write -1 times, and then the prime factorization for the number. So 361. I don't know if that number is prime or not. So if I punch up square root of 361 in a calculator, I actually get 19. So that tells me it's not prime because it's 19 times 19. So 19 is a prime number, so I put -1 times 19 times 19. Now for 152, I know that it's even, so it's at least divisible by 2. I know that 52 is divisible by 4, so I know 152 is divisible by 4. So let's start out with dividing 152 by 4 and see what we get. 4 goes into 15 3 times. 3 times 4 is 12. Subtracting, we get 3. Bring down the 2. 4 goes into 32 8 times. 8 times 4 is 32. Subtracting, get 0. So 38 times 4. 38 times 4. 152 is 38 times 4. 4 is 2 times 2. Those are both prime. We're going to circle them. Now 38 is 19 times 2. 19 is prime, and so is 2. So our prime factorization would be 2 times 2 times 2 times 19. Now, I can cancel this factor of 19 with this factor of 19. And I'm going to be left with -1 times 19, or -19, over 2 times 2 times 2, or 8. So I get -19 eighths. All right, what about 80 over 130? So 80 over 130. Well, 80 I know is 8 times 10. And 8 is 2 times 2 times 2. And then 10 is 5 times 2. So I'm going to put times 2 times 5. What about 130? Well, I know it's 13 times 10. Right? So 13 times 5 times 2. So essentially the greatest common divisor between 80 and 130 is 10. So again, if I realize that to start, I can just say, okay, 80 divided by 10 is 8. 130 divided by 10 is 13. And I would have my answer that quick. But again, doing it this way, we cancel 1 factor 2 in the numerator with 1 factor 2 in the denominator, 1 factor 5 in the numerator with 1 factor 5 in the denominator, and we have our answer. 2 times 2 times 2 are 8 over 13. And again, we get 8/13. Hello and welcome to Pre-Algebra Test Section 3 on simplifying fractions. So we just want to reduce each fraction to its lowest terms. And we're going to start out with 119 over 49. So the first thing we always want to do is factor the numerator and denominator completely. I know that 49 is 7 times 7. 119 I don't work with that often. So it might be a prime number, it might not be. If I take the square root of 119, I get about 10.90. So the next highest whole number would be 11. So let's check for divisibility by all the prime numbers up to and including 11. So I'm going to check 2, 3, 5, 7, and then 11. So it's not even, so it's not divisible by 2. 1 plus 1 is 2, 2 plus 9 is 11, not divisible by 3. Final digit's not a 0 or 5, so not divisible by 5. Let's check 7. So I would cut the 9 off and I would double it. 9 times 2 is 18. So essentially I would have 11 minus 18. Now that's going to give me -7. Now -7 is divisible by 7, right? -7 divided by 7 is -1, no remainder. So that tells me this number is divisible by 7. So 119 divided by 7. 7 goes into 11 once. 1 times 7 is 7. Subtracting, get 4. Bring down the 9. 7 goes into 49 7 times. 7 times 7 is 49. Subtracting, get 0. So 17, which is a prime number, times 7 gives me 119. Now what we want to do is cancel the common factors between the numerator and denominator. So I can cancel this 7 with this 7. And what's left is a 17 in the numerator over a 7 in the denominator, or 17 sevenths. All right, what about 9 over -57? So again, factor the numerator and denominator completely. 9 I know is 3 times 3. -57, when we have a negative number, just write -1 and then factor 57. Now 57 is going to be 19 times 3. 19 times 3. And we can cancel now a common factor of 3 between numerator and denominator. And we end up with a 3 in the numerator over a -1 times 19, or -19 in the denominator. When you have a negative number in the denominator, you can switch it up and write a negative in the numerator and a positive in the denominator. So I could also write negative 3 over 19, or I could just write the negative out in front and put 3 over 19. These are all the same. Positive divided by negative is negative. Negative divided by positive is negative. And just putting a negative out here, it's all the same. So you get negative 3 over 19 or negative 3/19 as your answer. All right, for the last one, we have 45 over negative 100. So I know 45 is 5 times 9, and 9 is 3 times 3. For negative 100, I'm going to put negative 1 times 100. I can do 10 times 10, and I know 10 is 5 times 2. So basically 5 times 5 times 2 times 2. And I can cancel a factor of 5 in the numerator with a factor of 5 in the denominator, and that's all I can do. So I'm going to end up with 3 times 3 or 9 in my numerator over negative 1 times 5 times 2 times 2 in the denominator. 5 times 2 is 10, 10 times 2 is 20, then times negative 1 is negative 20. And again, I can write this as negative 9 over 20, or I could also write this as negative 9/20. All of these are the same. Again, positive divided by negative is negative. Negative divided by positive is negative, or negative out in front. You're all just signaling that the number is negative. So negative 9/20 is our answer. Hello and welcome to Pre-Algebra Test Section 4 on simplifying fractions. So we want to just reduce each fraction to its lowest terms. So we're going to begin with 154 over 209. And the first thing we want to do is factor the numerator and denominator completely. So for 154, I don't know the prime factorization of that number off the top of my head. I'm just going to use a little factor tree to help myself out. I know it's divisible by 2. So what is 154 divided by 2? 2 goes into 15 7 times. 7 times 2 is 14. Subtract and get 1. Bring down the 4. 2 goes into 14 7 times. 7 times 2 is 14. Subtract and get 0. So 2 times 77. Now 2 is prime, so I'm going to circle that. And 77 I know is 7 times 11. So I'm going to circle 7 and circle 11. So my prime factorization for 154 is 2 times 7 times 11. What about 209? I don't work with that number very often. One thing I'm going to tell you is when you get a problem like this on your homework or on a test, look at this number. We know it's not even, so it's not divisible by 2. If it's going to be able to be simplified, it has to be divisible by a 7 or an 11. So just check those two numbers. So is 209 divisible by 7? Cut off the final digit of the number. So you'd have a 20, cut off the 9, and double it. If I double 9, I get 18. If I subtract that away, I get 2. So it's not going to be divisible by 7. Is it divisible by 11? So again, you number the digits. So you have 2, 0, 9. This is 1, this is 2, and this is 3. So form the sum of the digits in the odd positions. So we have 2, which is in the first position, plus 9, which is in the third position, so that's 11. We're subtracting away the sum of the digits from the even positions. I just have a 0 that's in an even position, and that position is in the second position of the number. So I'm subtracting away a 0. 11 minus 0 is 11. So because this is an 11, and 11 is divisible by 11, we know that 209 is divisible by 11. So let's do that. So 209 divided by 11. 11 goes into 20 once. 1 times 11 is 11. Subtract and get 9. Bring down the 9. 11 goes into 99 9 times. 9 times 11 is 99. Subtract and get 0. So we'd have 11 times 19. Both numbers are prime. So now we see we can cancel a factor of 11 in the numerator with a factor of 11 in the denominator. And we end up with 2 times 7 or 14 over 19. So 14/19 is your simplified version of this fraction, 154 over 209. So what about 13 over 19? So occasionally we're going to get problems that we can't simplify. So 13 is a prime number, and so is 19. So there's really nothing I can do because the greatest common factor, or the greatest common divisor of 13 and 19 is 1. So that tells me that there's nothing I can really do to simplify this fraction. What about 80 over 32? 80 over 32. Well, I can factor 80. I know that it's 16 times 5, and 16 is 4 factors of 2. And 32 I know is 5 factors of 2. But once you get good at this, you're going to know that the greatest common divisor of 80 and 32 is 16. And if you realize that, I could just divide 80 by 16 and get 5, and divide 32 by 16 and get 2, and realize I'm going to have 5 halves. So when we look at it this way, we're just going through and canceling things. We're saying, okay, this 2 cancels with this 2, this 2 cancels with this 2, this 2 cancels with this 2, and this 2 cancels with this 2. But essentially, I have canceled a factor of 16 from the numerator with a factor of 16 from the denominator, which is the same as if I just said, what is 80 divided by 16? Right? It's going to be 5, which is what's left there. What is 32 divided by 16? Well, it's going to be 2, what's left there. So either way you do it, you end up with 5 halves as your answer. Hello and welcome to Pre-Algebra Test Section 5 on simplifying fractions. All right, so we just want to reduce each fraction to its lowest terms. So we're going to begin with negative 220 over 176. So the first thing we want to do is factor the numerator and denominator completely. And I have negative 220, so I'm just going to write negative 1 times the prime factorization of 220. Now I see that 220 ends in a 0. So I know it's 22 times 10. 22 is 11 times 2, and 10 is 5 times 2. What about 176? Well, I know that 76 is divisible by 4, so I know that 176 would be divisible by 4. So let's start out by doing that. 4 goes into 17 4 times. 4 times 4 is 16. Subtract them, we get 1. Bring down the 6. 4 goes into 16 4 times. 4 times 4 is 16. Subtract and get 0. So 44 times 4. 44 times 4. So 4 is 2 times 2. 44 is 11 times 4. 4 is 2 times 2 again. So now I'm looking for common factors between numerator and denominator that I can cancel. I can cancel this 11 with this 11. I can cancel this 2 with this 2. And I can cancel this 2 with this 2. So what I have left is negative 1 times 5 or negative 5 in the numerator. In the denominator, I have 2 times 2 or 4. So this ends up being negative 5/4 for my answer. What about 84 over 96? Well, what is 84? I know that it's divisible by 4, so let's start with that. 4 goes in 8 twice. 2 times 4 is 8. Subtract, I get 0. Bring down the 4. 4 goes into 4 once. 1 times 4 is 4. Subtract and get 0. So 21 times 4. 4 is 2 times 2. And 21 is 7 times 3. What about 96? Well, I know that's also divisible by 4, so let's start with that. 4 goes into 9 twice. 2 times 4 is 8. Subtract and get 1. Bring down the 6. 4 goes into 16 4 times. 4 times 4 is 16. Subtract and get 0. So 24 times 4. So 4 is 2 times 2. 24 is 4 times 6. 4 is 2 times 2. 6 is 2 times 3. So now let's look to see what we can cancel between the numerator and denominator. So I can cancel this 2 with this 2, this 2 with this 2, and this 3 with this 3. So we'll end up with 7 in the numerator over 2 times 2 times 2, or 8 in the denominator. So we get 7/8 as our answer. Okay, final problem. We have negative 28 over 119. So again, if I have a negative involved, I'm just going to write negative 1 times the prime factorization of that number. 28 is pretty easy. It's 7 times 4, and 4 is 2 times 2. So times 7 times 2 times 2. Well, what about 119? This is a number that we don't work with very often. So if you get this problem on your homework or your test, check to see if the 119 is divisible by 7. If it's not, you can't simplify this fraction. We know it's not divisible by 2. It's not an even number. So what is 119 divided by 7? 7 goes into 11 once. 1 times 7 is 7. Subtraction, you get 4. Bring down the 9. 7 goes into 49 7 times. 7 times 7 is 49. Subtracting, get 0. So 17 times 7. And again, if 119 wasn't divisible by 7, you would stop. The fraction would not be able to be simplified. So in this case, it is, because we have 17 times 7. So we're going to cancel this 7 with this 7, and then we're done. So we end up with negative 1 times 2 times 2, or negative 4 for the numerator, over 17 for the denominator. So we get negative 4/17 as our answer. Hello and welcome to Pre-Algebra Practice Set number 30. In this video, we're going to look at some additional practice problems for our lesson on multiplying fractions. All right, so we want to find each product. We're starting out with 5/6 times 8. So when we multiply a fraction by a whole number or by an integer, we can make it kind of mentally easier for us by just writing that whole number or that integer over the number 1. 8 over 1 is still 8. Whenever you divide a number by 1, it always remains unchanged. So now we can go through and multiply. And before we do that, we want to see if we can cross-cancel anything. So I know that between 5 and 1, there's nothing I can cancel. Between 8 and 6, both have a common factor of 2. So in other words, I can think about 8 as 4 times 2, and I can think about 6 as 3 times 2, and I can cancel this 2 with this 2, and what I'm left with is 5 times 4, or 20, for my numerator, over 3 times 1, right? 3 times 1, or 3, for my denominator. So the result is going to be 20/3, or you could say 20 over 3. What about 1/9 times 10/17? Again, I'm going to start out by looking to cross-cancel. Can I cancel anything between 9 and 10? No, I cannot. 9 is 3 times 3. 10 is 5 times 2. Can I cancel anything between 1 and 17? No, I cannot. So all I need to do in this case is just multiply the numerator by the numerator. So 1 times 10 is 10. And place that over the denominator times the denominator. What is 9 times 17? So 17 times 9. 9 times 7 is 63. 9 times 1 is 9, plus 6 is 15. So we would get 10 over 153 as our answer. What about 10 times -3/2? Well, again, if you have a whole number hanging out there, you can write it over 1 to make it mentally easier to multiply these fractions. Now, is there anything I can cross-cancel here? Well, yeah, if I look, I can see that 10 and 2 are going to have some factors in common. So 10 is 5 times 2, so I could do this and say, okay, this is 5 times 2, and I could cancel this 2 with this 2. Or kind of a quicker way to do this, just think about, okay, I know that 10 divided by 2 would be 5. So I can just cross this out and put a 5, cross this out and put a 1, right? Divide each of those by the number 2. Again, 10 divided by 2 is 5, 2 divided by 2 is 1. It's really all you need to do. Now, there's nothing else I can cancel here, so I just do my multiplication. 5, which is what's left in the numerator, times -3 is -15. I have a 1 here and a 1 here after my result of canceling. So 1 times 1 is 1. So I get -15 over 1, or just -15. All right, what about -9/8 times 7/18? So what we want to look to do is see if we can cross-cancel anything first. So I know I can't cancel anything between 8 and 7. 8 is 3 factors of 2. 7 is a prime number. But between -9 and 18, I can do some canceling. Forget about the negative for now. Just think about this as -1 times 9. I know that 18 divided by 9 is 2. So 18 divided by 9 is 2. 9 divided by 9 is 1. So essentially I would just have -1 here times 7. So that's -7. And down here I'd have 8 times 2. And that's 16. So my result would be -7/16. What about -15 times 17/20? So I can write -15 as -15 over 1. And then see what I can cross-cancel. I can't do anything between 1 and 17, but I can cancel between -15 and 20. Again, just forget about that negative for a minute. Just say -1 times 15. I know that 15 is 5 times 3, and I know 20 is 5 times 4. So here's where we're really going to speed some stuff up. If I divide 20 by 5, I get 4. If I divide 15 by 5, I get 3. So now I have -1 times 3, that's -3, times 17. So what is -3 times 17? We know that's negative, and then 17 times 3. 3 times 7 is 21. 3 times 1 is 3, plus 2 is 5. So that's -51 for my numerator. My denominator, I have 1 times 4, so that's just 4. So we get -51/4 as our answer. All right, let's take a look at 19/6 times 3/38 times 2/5. So immediately I'm looking to see what I can cross-cancel. And I can see that 6 divided by 3 would be 2. So essentially, again, 6 divided by 3 is 2. 3 divided by 3 is 1. Then I know that 38 divided by 19 would be 2. So 38 divided by 19 is 2. 19 divided by 19 is 1. Then I can cancel this 2 with this 2. And my numerator now will just be a 1. Right? I have 1 times 1 times 1. And that's 1. For my denominator, I have 2 times 1 times 5, or 10. So this ends up being 1/10 as my answer. All right, let's take a look at 7/10 times 5/2 times -4 times 3/49. So again, if it makes you feel more comfortable, you can write this -4 over 1. And we can just look to see what we can cross-cancel. So at this point, I can see that I can cancel this 10 with this 5, right? 10 divided by 5 is 2. So the result here, this 10 would be canceled and become a 2. This 5 would be canceled and become a 1, right? Again, 10 divided by 5 is 2. 5 divided by 5 is 1. Again, if it makes you feel more comfortable, you can write these out and say, okay, this is 5 times 2. Cancel this 5 with this 5, put a 1 here, and that's a 2. But I just think it's a little faster if you realize that 10 divided by 5 is 2. So this is going to go away, and this is going to become a 2. All right, the next thing we look at is, I know that 49 divided by 7 is 7. So this would become 7. Right? If I divide 49 by 7, I get 7. And this would be 1. If I divide 7 by 7, I get 1. Now continuing, I have this negative 4 here. And what I'm going to do is I'm going to write this as negative 1 times 4. Cross that out. And I can see that I have a 2 and another 2. 2 times 2 is 4. So I can cancel this 2 and this 2 with this 4. Right? 2 times 2 again is 4. It's the same thing as if I had a 4 hanging out there and I just canceled it with that 4. So both of these are just going to be a 1. So I have 1 times 1 times 1 times 7 in the denominator. That's just going to be 7. In the numerator, I'm going to have 1 times negative 1 times 3. So that's just going to be negative 3. And up with negative 3 over 7. Or again, you can write this as negative 3/7 like this. Or you can even write 3 over negative 7. Whatever you want to do. Again, positive divided by negative or negative divided by positive is a negative. All right, let's take a look at 1 over 42 times 7/9 times negative 3 times 2/5 times negative 2/7. So I can write this negative 3 as negative 3 over 1. And then we can look to see what we can cross cancel here. So I know 42 divided by 7 is 6. So 42 divided by 7 is 6. 7 divided by 7 is 1. Again, just canceling a common factor of 7. I know that 9 divided by 3 is 3. I know this is negative 3, but I'm just going to forget about this for a second and say 9 divided by 3 is 3. 3 divided by 3 is 1. So this is just going to be negative 1 as a result up there. Then what do I have left? I have this 2 and I have this negative 2. Now 6 divided by 2 is 3. So I can cancel this out, put a 1, and cancel this out and put a 3. Right? Again, 6 divided by 2 would be 3. 2 divided by 2 would be 1. So that's all I can cancel. In my numerator, so we'd have 1 times negative 1 times 1. That's negative 1. Times negative 2. That's going to be positive 2. Over. We have 3 times 3 or 9. Times 1, which is still 9. Times 5, which is 45. Times 7. 7 times 5 is 35. 7 times 4 is 28, plus 3 is 31. So that's 315. So our answer here is going to be 2 over 315. So let's take a look at a word problem to kind of wrap up our practice set. So Brandy works on a team that must write 1/4 of the 28 pages in a report. How many pages does the team need to write? Well, basically all we need to do is multiply 1/4 times 28. All right, so what is 28 times 1/4? And again, if it makes you feel more comfortable, write it as 28 over 1. I can cross cancel between the 28 and the 4. 28 divided by 4 is 7. So cancel this, it'll become a 7. Cancel this, it'll become a 1. And basically you get 7 times 1, which is 7, over 1 times 1, which is 1. So the answer here is just 7. So to kind of formally answer this, when you get a word problem, you want to kind of answer it in words, you would say that her team is responsible for 7 pages of the report. Hello and welcome to Pre-Algebra Test Section 1 on multiplying fractions. So we just want to find each product. And we start out with 47 over 20 times 8 over 21. So when we multiply fractions, we want to start out by just looking to see if we can cross cancel anything. So when I look at 47, that's a prime number, so I can't really cancel it with 21, right? 21 is 7 times 3. 7 times 3. When I look at 20, I can think about that as 4 times 5, and think about 8 as 4 times 2. And what I can do is I can cancel a common factor of 4 between 8 and 20. So what I'd be left with is a numerator that's 47 times 2, or 94, over a denominator that's going to be 5 times 7 times 3. So 5 times 7 is 35. 35 times 3 is 105. So our answer here is going to be 94 over 105. For the next one, we look at 35 over 34 times negative 27 over 37. So what can we cross cancel here? Well, if I look at 34, it's 17 times 2. If I look at 35, it's 5 times 7. If I look at negative 27, you can think about this as negative 1 times 3 times 3 times 3. And 37 is a prime number. So if I look between 34 and negative 27, no factors that are in common. If I look between 35 and 37, obviously there's nothing in common because 37 is a prime number. So we just go ahead and do the multiplication. So we know the result's going to be negative here in the numerator. And we would do 35 times 27. 7 times 5 is 35. 7 times 3 is 21, plus 3 is 24. 2 times 5 is 10. 2 times 3 is 6, plus 1 is 7. So this is a 5, and we bring this down. 4 plus 0 is 4. 2 plus 7 is 9. So we get negative 945 for our numerator. For the denominator, we multiply 34 by 37. 7 times 4 is 28. 7 times 3 is 21, plus 2 is 23. 3 times 4 is 12. 3 times 3 is 9, plus 1 is 10. So bring down the 8. 3 plus 2 is 5. 2 plus 0 is 2. Bring down the 1. We get 1,258 there. So the answer would be negative 945 over 1,258. Okay, for the last one, we have 16 over 25 times 15 over 46. So there are some things we can cross cancel here. I know that 25 is 5 times 5, and I know 15 is 5 times 3. So if you think about the greatest common divisor, or the greatest common factor, for 25 and 15, it's 5. So just divide each number by 5. 25 divided by 5 is 5. 15 divided by 5 is 3. Another way you could have done that is just think about you're removing a factor of 5. So if 25 is 5 times 5, if I cancel one of the 5s, I'm left with 5. 15 is 5 times 3, so if I cancel a 5, I'm left with a 3. Now, what about 16 and 46? I know that 16 is 4 factors of 2, and 46 is 23 times 2. So the greatest common divisor between these two numbers is going to be 2. So just divide each number by 2. 46 divided by 2 would be 23. 16 divided by 2 would be 8. And that's all we can do. Now we multiply numerator by numerator. 8 times 3 is 24. And we put the result over denominator times denominator. 5 times 23. 5 times 3 is 15. 5 times 2 is 10, plus 1 is 11. So we get 24 over 115 as our answer. Hello and welcome to Pre-Algebra Test Section 2 on multiplying fractions. All right, so we just want to find each product. We're going to start out with 50 over 21 times negative 49 over 25. So the first thing we're doing when we're multiplying fractions is we're looking to cross cancel. Remember, we want to report our answer as a simplified fraction or as a fraction that's reduced to its lowest terms. So if I look between 50 and 25, I know that 50 divided by 25 is 2. So divide 50 by 25, you get 2. Divide 25 by 25, you get 1. So I'm just canceling a common factor of 25, or 2 factors of 5, between those two numbers. Now if I look at 21 and negative 49, I know that each number there is divisible by 7. So if I divide 21 by 7, I would get 3. If I divide negative 49 by 7, I would get negative 7. And now I'm done. There's nothing else I can cancel, so I just multiply numerator by numerator. 2 times negative 7 is negative 14. And I multiply denominator times denominator. 3 times 1 is 3. So I end up with negative 14 thirds, or just negative 14 over 3. What about 35 thirteenths times 39 over 56? Well, again, we're looking to cross cancel before we begin. If I look at 35, it's 5 times 7. And 56 is 8 times 7. Right? I know it's 2 times 2 times 2 times 7, but since this isn't divisible by 2, why bother breaking that 8 down further? Right? You want to do some things that kind of speed up your process. Now I can see I can cancel a common factor of 7 between 35 and 56. So just think about dividing 35 by 7, you would get 5. Right? You'd get 5, right? This would go away. Think about dividing 56 by 7, you would get 8, right? That would go away. What about between 39 and 13? Well, 39 divided by 13 is 3. So this would be a 3, and this would be a 1. Now I would have a 5 over here times a 3 over here. That's 15. And then a 1 over here times an 8 over here. That's 8. So we end up with 15/8 as our answer. All right, let's take a look at 12/17 times 1/18 times 34 over 35. Now when we look to cross cancel, the only thing that I can see right away is that 17 and 34 can be canceled. The result would be a 2 up here, right? Because 34 divided by 17 is 2. Since this is gone, now I just need to think about 18. That is going to be 6 times 3. 6 times 3, and 6 is 3 times 2. So 3 times 3 times 2. 12 I know I can write as 3 times 4 or 3 times 2 times 2. Now I can do some canceling between these two. I can basically cancel a factor of 6. Cancel a factor of 6 or 3 times 2. So I'm left with a 2 here and a 3 here. Now this is a 1 and this is 35, so that's 5 times 7. I really can't do anything with that 35, so I'm not even going to factor it. So now I'm just going to look to multiply. 2 times 1 times 2 is 4. Over, this is a 1, this is a 3. 1 times 3 is 3. Then times 35 would be 105. So our answer here is going to be 4 over 105. Hello and welcome to Pre-Algebra Test Section 3 on multiplying fractions. So we just want to find each product. And we're going to start out with -9 times 1/8 times 4/3 times 12/13. So again, if you have an integer or a whole number and you're multiplying by fractions, just go ahead and write it over the number 1. Remember, -9 divided by 1 is still -9. You have not changed the value of the number. You're just making it mentally easier to deal with these fractions. Now before we multiply, we want to go through and see what we can cross cancel. So when I start out, I can immediately see that I can remove a common factor of 4 between the 8 in the denominator here and the 4 in the numerator here. So 8 divided by 4 would be 2, 4 divided by 4 would be 1. Now next I can see that I can remove a common factor of 3 between this 12 and this 3. 12 divided by 3 would be 4. 3 divided by 3 would be 1. And then looking, I see that I have a 4 here and a 2 here. So 4 divided by 2 would be 2. So I can further cancel this guy. Further cancel this to make this a 2. This would cancel and become a 1. So now my denominators are a 1, a 1, a 1, and a 13. And then up here I have for numerators a -9, a 1, a 1, and a 2. So I can't cancel anything else. So now I just multiply all the numerators together. -9 times 1 is -9. Then times 2 is -18. Put that over the product of the denominators. So we have 1 times 1 times 1 times 13, or just 13. So we're going to get -18 over 13 as our answer. All right, for the last problem, we have -1/4 times 5/9 times 8/15 times -6/25. So just looking to see what we can cross cancel, I see again that I have 4 and 8. I know that 8 divided by 4 is 2, so that one's an easy one. 8 divided by 4 is 2. That's what I'm going to have up here if I remove a factor of 4. 4 divided by 4 is 1. If I remove a factor of 4, just think about this as 4 times 1. Remove that factor of 4, you just have a 1 left. All right, next I'm going to look at, I have 5 and I have 25. 25 divided by 5 is 5. So 5 divided by 5 is 1. 25 divided by 5 is 5. And what else do we have here? I have a 15 and I have a -6. So I could write 15 as 5 times 3. And I could write -6 as -1 times 2 times 3. And I can go ahead and cancel this 3 with this 3. And I'll just be left with a 5 here and then a -1 times 2 up there. Anything else we can cancel? This is 9. This is 3 times 3. No more 3's up here. This is a 5. No more 5's up here. And then this is a 5. No more 5's up here. So nothing else we can really cancel. So the numerator will have -1 times 1 times 2. That's going to give me -2 times -1, which is going to be +2, then times 2, which is going to be 4. For the denominator, I've got 1 times 3 times 3. So that's 9 times 5. That's 45 times 5. 5 times 5 is 25. 5 times 4 is 20, plus 2 is 22. So we're going to get 225 as our result there. And our answer is 4 over 225. Hello and welcome to Pre-Algebra Test Section 4 on multiplying fractions. Okay, so we just want to find each product. For the first problem, we have 23 over 37 times 49 over 46 times negative 111 over 7 times 3/14. So again, before we go through and multiply numerators and put the result over the product of the denominators, we want to look to see what we can cross cancel. Remember, when we report our answer, it needs to be simplified. So if I look, immediately I see that I have 23 in the numerator here and 46 in the denominator here. So 46 divided by 23 is 2. So if I divide each one by 23, this will become 2, this will become 1. Right? I'm just canceling a common factor of 23 between numerator and denominator. Next, I see that 49 divided by 7 would give me 7. Right? If I remove a factor of 7 between the numerator here, the denominator here, this would be 7, right? 49 divided by 7 is 7, and this would be 1. 7 divided by 7 is 1. Now I also see that I have a 14 here and a 7 here. So I can further cancel this. 7 divided by 7 is 1. 14 divided by 7 is 2. All right, so what do we have left in the numerator? We have a 1, a negative 111, and a 3. In the denominator, I have a 37, which is prime, a 2, a 1, and a 2. Can't do anything with this 3, but if I look at negative 111, I might be able to cancel with 37 if it's divisible by 37. I know it's divisible by 3 because the sum of its digits, 1 plus 1 plus 1, is 3. So what is 111 divided by 3? 3 goes into 11 3 times. 3 times 3 is 9. Subtract and get 2. Bring down the 1. And 3 goes into 21 7 times. 7 times 3 is 21. Subtract and get 0. So since this is 3 times 37, and I know it's negative, so let's just put negative 1 times 3 times 37, we can cancel with this 37 over here. So I can cancel this 37 with this 37, and essentially all I'm left with now is 1 times 1 times negative 1 times 3 times 3. So 3 times 3 is 9, then times negative 1 would be negative 9, so you'd have negative 9 here, over. In the denominators, you've got 1 times 2, that's 2, times 1, that's still 2, times 2 again, that's 4. So we'll end up with negative 9/4 as our answer. Hello and welcome to Pre-Algebra Test Section 5 on multiplying fractions. All right, so we just want to solve each word problem. So Ralph invited 15 people to his party. 2/3 of the people invited attended the party. How many people came to the event? So to find out the answer to this question, we simply need to multiply 15, the number of people he invited to his party, by 2/3, and this is the fractional amount of people that were invited that actually showed up. So 15 times 2/3. Let's put this as 15 over 1. We can cross cancel here. 15 divided by 3 is 5. Right? 15 divided by 3 is 5. 3 divided by 3 is 1. So essentially I have 5 times 2, which is 10, over 1, which just equals 10. Now when we have a word problem, we want to give a nice little sentence as our answer. So how many people came to the event? 10 people. 10 people came to Ralph's party. Let's take a look at another one. Jacob has $63 in his checking account. He visits a local store and spends 1/9 of that money on food. How much is left in Jacob's checking account after his trip to the store? So the first thing we're told is that Jacob has $63 in his checking account. So let's highlight that. So this is kind of where he's going to start out at. So Jacob starts with $63. Now, we need to find out how much he spends at the store so we can subtract it away and find out how much he has in his checking account after his trip to the store. So he spends 1/9 of that money on food. So what is 1/9 of 63? We'd multiply to figure that out. So 63 times 1/9. And again, we could write this as 63 over 1. You can see that 63 divided by 9 is 7. Right? So I would cancel this with this, and I'd have 7 over 1 there. Right? 63 divided by 9 is 7. 9 divided by 9 is 1. So I'd have 7 times 1, or 7, over 1 times 1, or 1. So some of you would give the incorrect answer and say that he has $7 left. That's wrong. He spent $7 at the store. So Jacob spends $7. If we go back and reread the problem, you'll see that that's completely clear. Jacob has $63 in his checking account. He visits a local store and spends 1/9 of that money on food. So he spent $7 on food. Now, how much is left in Jacob's checking account after his trip to the store? We just need to take and subtract 7 away from 63. So 63 minus 7. We'd borrow here. 13 minus 7 is 6. Bring down the 5. He's going to have $56. So Jacob will have $56 in his checking account after his trip to the store. Hello and welcome to Pre-Algebra Practice Set number 31. In this video, we're going to look at some additional practice problems for our lesson on dividing fractions. So we're going to start out, we want to find each reciprocal. So we have 1/9. So to find the reciprocal, we just interchange the numerator and denominator. So we take the 9 that's in the denominator, bring it up to the numerator. We take the 1 in the numerator, bring it down to the denominator. And again, the way you check this, a number times its reciprocal is always 1. So if you take 1/9 and you multiply it by 9 over 1, and the result is 1, you have found the reciprocal. So we can cross cancel this 9 with this 9, and we'd have 1 over 1 times 1 over 1, which in fact would give us 1 as our answer. All right, what about 8/7? 8/7. Again, take the 7 from the denominator, bring it up to the numerator. Then take the 8 from the numerator, bring it down to the denominator. So the reciprocal of 8/7 is 7/8. What about the number 13? Well, whenever you work with a whole number or an integer, you're simply going to take that number and write it over 1. Now, once you've done that, you basically took the same number and made it into a fraction. 13 over 1 is still 13. Dividing by 1 leaves the number unchanged. But now I can take the denominator and bring it into the numerator, and I can take the numerator and bring it down to the denominator, and so the reciprocal of 13 is 1/13. What about 12/17? Again, you're just going to interchange the numerator with the denominator. So the 12 is going to come down to the denominator, and the 17 is going to go up to the numerator. So the reciprocal of 12/17 is 17/12. What about -5/3? Again, if you have a negative involved, you can just drag it down. So in this case, it's in the numerator. You can just drag it down to the denominator and then drag 3 up to the numerator. Or it's also correct if you say that the reciprocal is -3 over 5. It really doesn't matter because when you think about negatives, a negative divided by a positive, like in this case, is still a negative. In this case, a positive divided by a negative is also just a negative. At the end of the day, we have a -3/5 for this fraction here. That's our reciprocal. What about -2/5? Again, take this 5, bring it up to the numerator. Take this -2, and we'll bring that down to the denominator. And we'll end up with -5/2, or as I have it written here, 5 over -2. Again, when you're dividing a positive by a negative, you get a negative. So that's why I said -5/2 is your answer. Okay, then we have 11 over -12. So again, bring this up here. So I'll have -12. Bring this down here. I'll have 11. So -12 over 11, or -12/11 is your reciprocal. Okay, now we have 5. So when we have a whole number, we're just going to write it over 1. Bring this into the numerator. Bring this down to the denominator. And the reciprocal of 5 is 1/5. For the last problem, we have -1. Again, just write it over 1. Bring this into the numerator. Bring this down into the denominator. And the reciprocal of -1 is 1 over -1, which is still -1. You might say, okay, well, that's not the reciprocal of -1. Well, yes, it is. By definition, a number times its reciprocal will give you 1. So if I have -1 times -1, I do in fact get the number 1. Okay, let's practice some actual division problems. So we just want to divide. We're going to start out with 1/5 divided by 10/11. So to divide fractions, we take the first fraction, or the leftmost fraction, and we leave that guy unchanged. So we're going to have 1/5 there. Then we're going to multiply by the reciprocal of the second fraction, or the fraction on the right. So the reciprocal of 10 elevenths is 11 tenths. And when we multiply, we just look to cross cancel first. Nothing we can really cancel here, so we just do our multiplication. 1 times 11 is 11. 5 times 10 is 50. So we end up with 11 over 50 as our answer. Now, if you're unsure, remember, you can always check your division using multiplication. If you have something like 4 divided by 2 and you get 2, you can work backwards and say, okay, well, that means that 2 times 2 equals 4. So the same is true here. If we take 11 over 50 and we multiply it by the divisor, we should get 1/5, right? Our dividend back. Cross cancel the 50 and the 10. We can cross cancel this. 50 divided by 10 is 5. This would be 1. 11 cancels with 11. And so I'd end up with 1 times 1 or 1 over 5 times 1 or 5. Yeah, I do get 1/5 back. So my 11 over 50 is the correct answer. All right, what about negative 2/3 divided by 1/9? So we'd have negative 2/3. That part's going to stay unchanged. Then we're multiplying by, take the reciprocal of 1/9. That's going to be 9 over 1. Now I can do some cross canceling. I can cancel this 9 with this 3. That's going to give me a 3, right? 9 divided by 3 is 3. And then 3 divided by 3 is 1. All right, so we'd have negative 2 times 3, that's negative 6, over 1 times 1, or 1. And negative 6 over 1 is just negative 6. What about 9/13 divided by 39 over 40? So again, the leftmost fraction stays unchanged. And we multiply it by the reciprocal of 39 over 40. So that's going to be 40 over 39. And let's see, can we cross cancel anything? I know I can't cancel between 13 and 40. But I can cancel between 9 and 39. 9 is 3 times 3. 39 is 13 times 3. So I can divide each of these by the greatest common divisor, which is 3. 39 divided by 3 is 13. 9 divided by 3 is 3. Now I can do my multiplication. 3 times 40 is 120. Over 13 times 13, which is 169. So we'd end up with 120 over 169 as our answer. All right, what about 6 divided by 1/2? So when we work with whole numbers or integers and fractions, we just write these whole numbers or integers over the number 1 just to make it more convenient for us. So 6 over 1 is going to stay unchanged. And I'm dividing by 1/2, so I'm going to multiply by the reciprocal of this. So I'm multiplying by 2 over 1, which is just 2. Now in this case, really I could just drop the over 1s here because we just have the multiplication problem 6 times 2. And 6 times 2 is just 12. What about negative 5 divided by 1/8? Well, again, I can write this as over 1. So I'd have negative 5 over 1 times the reciprocal of 1/8, which is 8 over 1. And again, I could drop the 1s if I want, because I know I just have negative 5 times 8, and that is negative 40. All right, let's take a look at one more problem. And you'll notice we have 3 fractions involved. When this happens, we're just going to work left to right. So in other words, we're just going to treat this as a separate problem first. Once we get this result, then we'll divide by 27 over negative 20. So again, we're going to start with 4/5 divided by 8/9. So 4/5 times reciprocal of 8/9 is 9/8. Can we cross cancel? Yes. 8 divided by 4 is 2. So this will be 2. 4 divided by 4 is 1. Can't cross cancel anymore. We basically have 1 times 9 or 9 over 5 times 2 or 10. So what we have is 9/10 divided by 27 over negative 20. So now 9/10 is going to stay unchanged, and we're going to multiply by the reciprocal of 27 over negative 20. So that's going to be negative 20 over 27. And I think about 20 and 10. I'm going to ignore this negative for right now. I think about 20 and 10. 20 divided by 10 is 2. So I'm just going to go ahead and cancel this with this. This will be 1. This will be 2. So this will be negative 2 now. And then 27 divided by 9 is 3. So this will be 3, and this will be 1. So this fraction has completely canceled itself out. It's just worth 1 now. So I'd have 1 times, I'd have negative 2/3. So the answer here is just negative 2/3. Hello and welcome to Pre-Algebra Test Section 1 on dividing fractions. So we just want to find the reciprocal. So we're going to start out with 7/4. So to find the reciprocal of a number, you interchange the numerator and the denominator. So for 7/4, I just take 4 and take it from the denominator, bring it up to the numerator. I take 7 from the numerator, bring it down to the denominator, and end up with 4/7. And again, the way you can check this, a number times its reciprocal is always 1. So 7/4 times 4/7 should be 1. And you can see that you can cancel this 7 with this 7. It would give you 1. This 4 with this 4 would give you 1. You basically have 1 times 1, which is 1. What about 2/3? Again, interchange the numerator and denominator. So the 3 is going to go up top. The 2 is going to go to the bottom. And you get 3/2. What about -5? Well, if you have an integer or whole number, you can just write it over 1. Remember, if I divide something by 1, it remains unchanged. Now I can take the denominator and pull it up to the numerator, and I can take the numerator and pull it down to the denominator. So my reciprocal is 1 over -5, or you could really think of this as just -1/5, right? If I have a negative down here, positive divided by negative is negative overall, so I could just say this is -1/5. What about 8? Well, again, write it as 8 over 1, then bring the denominator up to the numerator, and the numerator down to the denominator, and I get 1/8. What about 9/14? Take the numerator, bring it down to the denominator. Take the denominator, bring it up to the numerator. So the reciprocal here is going to be 14/9. For the final problem, we have 11/13. Again, take the denominator, bring it up to the numerator. Take the numerator, bring it down to the denominator, and we get 13/11. Hello and welcome to Pre-Algebra Test Section 2 on dividing fractions. So we just want to divide, and we're going to have 1/2 divided by 1/4 to start. So to divide fractions, I take my leftmost fraction, which in this case is 1/2, and I multiply it by the reciprocal of the rightmost fraction. In this case, that's 1/4. So the reciprocal of 1/4 is 4 over 1. Now before I multiply, I can look to cross cancel. 4 divided by 2 is 2, so this 4 would become 2, this 2 would become 1. Right? I just divided by the greatest common divisor, again, which was 2. 4 divided by 2 is 2, 2 divided by 2 is 1. So now I can multiply. 1 times 2 is 2, over 1 times 1 is 1, so we get 2 over 1, or 2, as our answer. And remember, if you want to check this, take 2 and multiply it by 1/4, and you should get 1/2. So I'll write 2 as 2 over 1 times 1/4. This 2 would cancel with this 4. I'd have a 2 down here and a 1 up here. So 1 times 1 is 1, over 1 times 2 is 2. So you do in fact get 1/2 back. What about 2/7 divided by 3? Well, for convenience, I'm going to write this as 3 over 1. And I'm going to take this first fraction, 2 over 7, and multiply it by the reciprocal of 3 over 1, which is 1/3. So now I'm just going to look to see if I can cross cancel. I can't do anything here, and I can't do anything there. So I just multiply. 2 times 1 is 2. 7 times 3 is 21. So I end up with 2 over 21 as my answer. For the last one, we have -4/5 divided by 8/9. So I'm going to take -4/5 and multiply it by the reciprocal of 8/9, which is 9 over 8. And look to see if I can cross cancel anything. Forget about this negative for a minute. 8 divided by 4 is 2. So if I cancel this with this, I'd have a 2 here and a 1 here. And remember, it's a negative, so that's going to be a -1. I can't cancel anything else. So -1 times 9 is -9. Over 5 times 2, that's 10. So I get -9/10 as my answer. Hello and welcome to Pre-Algebra Test Section 3 on dividing fractions. All right, so we just want to divide. We're going to start out with 9/28 divided by 12/35. So again, to divide fractions, we take the first fraction, and we leave that unchanged. And when I say first fraction, I mean the leftmost fraction. So we have 9/28 there, and we're going to multiply by the reciprocal of the second fraction, meaning the fraction on the right. So the reciprocal of 12 over 35 is 35 over 12. Now I'm going to look to see if I can cross cancel anything. I know the greatest common divisor between 9 and 12 would be 3. So if I divide each by 3, 9 divided by 3 is 3, 12 divided by 3 is 4. So basically I just removed a common factor of 3 from each. Now what about between 35 and 28? Well, the greatest common divisor is going to be 7. 28 divided by 7 would be 4. 35 divided by 7 would be 5. Nothing else I can really cancel, so now I just multiply. 3 times 5 is 15. 4 times 4 is 16. So I end up with 15 over 16 as my answer. Now remember, if you're ever unsure if you got the right answer, you can check division with multiplication. So 15 over 16, multiplied by the divisor, 12 over 35, should give me the dividend back. So it should give me 9/28 back. So between 16 and 12, the greatest common divisor is going to be a 4. So 16 divided by 4 is 4. 12 divided by 4 is 3. Between 15 and 35, the greatest common divisor is a 5. 15 divided by 5 is 3. 35 divided by 5 is 7. So if I multiply, 3 times 3 is 9. 4 times 7 is 28. We do in fact get back to this 9 over 28. Let's look at 8/3 divided by -1/9. So 8/3 stays the same. And we're multiplying by the reciprocal of -1/9. So that's going to be 9 over -1. Or we could put -9 over 1. It doesn't really matter. So we look to cross cancel. Cancel this 9 with this 3. 9 divided by 3 is 3. So this is going to be a 1. This is going to be a 3. All right, I just removed a factor of 3 from each of those. And then I can't cancel anything else, so I'm just going to multiply. 8 times 3 is 24. 1 times -1 is -1. So I get 24 over -1, or basically just -24. All right, for the last problem, we have 4/7 divided by 3/14. So the first fraction, the 4/7, stays unchanged. Then I'm going to change my division to multiplication, and I'm going to be multiplying by the reciprocal of 3/14. So that's going to be 14/3. Now what can I cross cancel here? I know that 14 divided by 7 is 2. So this will be 2. 7 divided by 7 is 1. Right? I'm just removing a factor of 7. And then I can't cancel anything else, so I just multiply. 4 times 2 is 8. And then 1 times 3 is 3. So we get 8/3 as our answer. Hello and welcome to Pre-Algebra Test Section 4 on dividing fractions. Okay, so we just want to divide. And we have 7 divided by -1/5. So what we're going to do is we're going to write 7 as 7 over 1. And we're going to keep that number unchanged. Now we're going to multiply by the reciprocal of this fraction here. The reciprocal of -1/5 is 5 over -1, where you really could put -5 over 1. And we're just going to multiply here. Nothing we can cancel. 7 times 5 is 35. 1 times -1 is -1. So in the end, we just get -35 as our answer. Right? 35 over -1 is just -35. What about 2/3 divided by 10? So I'm going to write this as 10 over 1. And the first number is going to stay unchanged. I'm going to multiply by the reciprocal of 10 over 1, which is 1/10. Look to cross cancel anything. I can cancel this 10 with this 2. That will give me a 5 here and a 1 here. Right? 10 divided by 2 is 5. And so I'd have 1 times 1, or 1 in the numerator, over 3 times 5, or 15 in the denominator. And so my answer here is 1/15. For the last one, I have 5/4 divided by 20. So I'll write this as 20 over 1. I'll have 5/4. That stays unchanged. And then I'm multiplying by the reciprocal of 20 over 1, which is 1 over 20. Now I can cross cancel here. Think about 20 divided by 5 would give me 4. So 5 over 5 is 1. 20 over 5 again is 4. And now I just multiply. 1 times 1 is 1. Over 4 times 4, that's 16. Hello and welcome to Pre-Algebra Test Section 5 on dividing fractions. All right, so we just want to divide. We're looking at -1/3 divided by 1/2 divided by 2/7. Now, when we have 3 fractions involved, we're just going to use the order of operations. We go left to right. So we're going to tackle this part first. So -1/3 divided by 1/2. We'll get a result, and we'll divide that by 2/7. So -1/3 divided by 1/2. This fraction, -1/3, stays unchanged. We're going to multiply by the reciprocal of 1/2, which is 2 over 1. Nothing to cancel, so we'd end up with -2 over 3. So we're going to put up here that this is going to be -2/3 divided by 2/7. Now, we take this first fraction, -2/3, and we leave it alone. Then we're multiplying by the reciprocal of 2/7, which is 7 over 2. Now we can cross cancel here. Forget about this negative for a minute. 2 over 2 is 1. All right, so I'll put a 1 here and a 1 there. Remember that negative now, so that's going to be a -1. Nothing else to cancel, so we'll do -1 times 7, that's -7. Over 3 times 1, that's 3. So we get -7/3 as our answer. All right, for the last one, we have 5/9 divided by 20 over 21 divided by 3/4. So again, I'm going to do this part first, and then I'll take the result and divide by 3/4. So I'd have 5/9 times the reciprocal of 20 over 21. That's going to be 21 over 20. So the greatest common divisor of 5 and 20 is 5. So divide each of these by 5. So 5 divided by 5 is 1. 20 divided by 5 is 4. The greatest common divisor for 21 and 9 is going to be 3. So divide 21 by 3, you get 7. Divide 9 by 3, you get 3. And we're done canceling stuff. Now we can just multiply. 1 times 7 is 7. Over 3 times 4, that's 12. So we'd have 7/12 divided by 3/4. So now we're tackling 7/12 divided by 3/4. 7/12 remains unchanged. We're going to multiply by the reciprocal of 3/4, which is 4/3. And the greatest common divisor between 12 and 4 is 4. So 4 divided by 4 is 1. 12 divided by 4 is 3. And so now we're going to do 7 times 1, that's 7. Over 3 times 3, that's 9. And we get 7/9 as our answer. Hello and welcome to Pre-Algebra Practice Set number 32. In this video, we're going to look at some additional practice problems for our lesson on finding the LCM, otherwise known as finding the least common multiple. So to start out, we want to find the LCM by listing the multiples of each number. So this is the slower, more tedious method that we started our lesson out with. Basically, when we talk about the multiples of a number, we take the number and we multiply it by each non-zero whole number. So we'd start with 1 and kind of increase in increments of 1 out indefinitely. And that would generate a list of multiples for the number. So if I take the number 3, I'd multiply 3 times 1 to start. That would give me 3. Then I would do 3 times 2. That would give me 6. Then I would do 3 times 3. That would give me 9. And what I notice is that I'm just increasing in increments of 3. So then 12, then 15, then 18, then 21, so on and so forth. I'm just going to stop and put 3 dots there to tell me that pattern where I'm increasing in increments of 3 is going to continue forever. So the next one is 6. And basically we can use the same technique as we did here. If I did 6 times 1, I'd get 6. 6 times 2 would give me 12. Basically, I'm just increasing in increments of 6. Here I was increasing in increments of 3. Here I'm increasing in increments of 6. So then 18, then 24, then 30, then 36, then 42, then 48. And we'll go ahead and stop there. And finally, we have 12. So 12 times 1 is 12. And then we just increase in increments of 12 now. So 24, 36, 48, 60, 72, 84, 96, and we'll go ahead and stop there. So if we want to find the least common multiple, we not only have to look for what's common to all the lists, but also what's the least common to all the lists. So if I look through here, I would start by looking at 12. So 12 is a multiple of 12. It's also a multiple of 6, and it's a multiple of 3. So that's going to be my least common multiple. Now, once you've found the least common multiple, you know that if you take that number and you add it to 12, so if I take 12 and I add it to 12, that gives me 24. That's going to be my next common multiple. So it occurs at 24. And then add 12 again, so it would occur at 36. So you can see 36 here and here. You don't see it here because I didn't list all the numbers out, but you'd have 24, then 27, then 30, then 33, then 36. So then after that occur at 48. Again, every 12 numbers, you'd have a common multiple between 3, 6, and 12. But the least common multiple, and let me circle it because I have a lot of things highlighted here, would be 12. Right? That's the least common multiple. So this equals 12. All right, we're going to do one more using this method. So to generate a list of multiples for 10, I would just start out with the number 10 because 10 times 1 is 10. And then I just increase in increments of 10. So 20, 30, 40, 50, 60, 70, 80, 90, and let's stop at 100. Again, the 3 dots tell me that that pattern is going to continue forever. So increasing in increments of 10. Then next we have 15. So start with 15 times 1, that's 15. And then increase in increments of 15. So 30, then 45, then 60, then 75, then 90, then 105, then 120, then 135, and comma, dot, dot, dot. And lastly, we're doing 20. So start out with 20 times 1, that's 20. Then increase in increments of 20, so 40, 60, 80, 100, 120, 140, 160, 180, 200. And we will stop there. All right, so let's look for the least common multiple now. So the first number we can find is actually 60. And what you're going to find is that every 60 numbers after that, you're going to have a common multiple. So at 120, you would have a common multiple. Right, you have 120 here and here. And after 100 up here, you'd have 110, then 120. So that's a common multiple between 10, 15, and 20. Then add another 60 to that, you get to 180. That'd be your next common multiple. So every 60 numbers. But the least common multiple is going to be 60. All right, now we're going to find the LCM using the prime factorizations of the numbers. So we want to look for the LCM of 39 and 65. So in case you didn't watch the lesson, this is fairly simple. There's just one step that kind of trips people up, and when we get to it, I'll spend a lot of time on it. So the first thing you want to do is just find the prime factorization for each number. For 39, it's 13 times 3. 3 is prime and 13 is prime. For 65, it's 13 times 5. 13 is prime and so is 5. And once we have this, we build ourselves a nice little table. So I'll have 39 and 65. And what this table is going to do is it's going to help us to see what prime factors we have in common between the two prime factorizations. So I'm looking for my smallest prime factor, and that's a 3 that occurs in 39. So I'm going to put a 3 here. 65 doesn't have it, so I kind of make a notation that tells me, hey, 65 is missing a 3. Then I look for the next highest, that's a 5 that occurs in 65. So I'm going to put a 5 there, but I don't have it in 39, so I'm going to kind of X that out to say, hey, we don't have that in the prime factorization of 39. And basically the next thing we have is 13, and that is shared by both. Each has a 13 in its prime factorization. So now we're going to build our LCM. Once we have this little table set up, we can build out our LCM for 39 and 65. Basically, what we want to do is include every prime factor from each prime factorization. Now, hold on, there's a catch to that. So there's a 3 in the prime factorization of 39. That's going to go in here. There's a 5 in the prime factorization of 65. That's going to go in here. And then some of you might say, okay, there's one 13 and then a second 13 that need to go in here. But that would be wrong. Here's where students get tripped up. When you have a prime factor that is shared, meaning it's in both of your prime factorizations here, you only need to put in the largest number of repeats between the prime factorizations. In this case, I have 113 in the prime factorization. In this case, I also only have 1. So the largest number of repeats would be 1, so I just put one single 13 when I'm building my LCM. That's all I need to do. I can put another 13 in here if I want to. That would also be a common multiple, but it wouldn't be the least common multiple, and that's what we're looking for. So now what we want to do is just go through a multiply. 3 times 5 is 15. 15 times 13 is going to give us 195. So that's going to be my LCM for 39 and 65. All right, now we're looking at one with 3 numbers, and it's really not more difficult. So we have the LCM of 22, 28, and 36. So I'm just going to factor each one. So 22 is 2 times 11. Both those numbers are prime. 28, and let me just fix this real quick. 28 is 4 times 7. 7 is prime, 4 is 2 times 2. 2 is prime. 36, let's do 12 times 3. 3 is prime. 12 is 4 times 3. 3 is prime. 4 is 2 times 2. So now let's build ourselves a nice little table. So we've got 22, 28, and 36. So the smallest prime factor is 2. I've got one of those for 22. I've got 2 of those for 28. And I've got 2 of those for 36. So 1 for 22, 2 for 28, and 2 for 36. So I'm just going to box this guy out here. And going back up, the next smallest prime factor would be a 3. I have 2 of those in the prime factorization of 36, not matched anywhere else. So times 3 times 3. And I'm just going to X those guys out here. And then I have a 7 in the prime factorization of 28, not matched anywhere. And an 11 in the prime factorization of 22, not matched anywhere. So for 28, I'm putting times 7. And for 22, I'm putting times 11. And I'm going to go ahead and box these out here. So it's easy for us to see what we share. And looking at it, the only thing they really have in common, everything has 1, 2. And then between 28 and 36, they have a second 2 involved. So when we build our LCM for 22, 28, and 36, again, we want to include every prime factor from each and every prime factorization. The catch is when something is shared between, in this case we have 3 numbers, between at least 2 of the prime factorizations, we're only putting the largest number of repeats that occurs between any of the prime factorizations. So with the number 2, because it's shared, the largest number of repeats would be 2. You have 2 factors of 2 in 36, and you have 2 factors of 2 in 28. So when I build my list, I only put 2 factors of 2, and I move on. So now I see that I have 2 factors of 3 in 36, not matched anywhere, so I just throw that in there. I have 1 factor of 7 in 28, not matched, so I just throw it in there. And 1 factor of 11 in the prime factorization of 22, not matched, so I just throw it in there. Again, if they're not shared, you just throw it in. You don't have to worry about how many you're going to put in there. If they are shared, you use the largest number of repeats between any of the prime factorizations. Okay, so now we're just going to multiply. 2 times 2 is 4. 4 times 3 is 12. 12 times 3 is 36. 36 times 7 is 252. Then times 11 is going to give us 2,772 as our answer. All right, let's take a look at one final problem. We want to find the LCM for 55, 715, and 247. So we're going to factor each number. So 55 is pretty easy. We know that's 11 times 5. Both are prime. 715, I don't know. All I can see is that it ends in a 5. So I know that I can divide it by 5. So 715 divided by 5. 5 goes into 7 once. 1 times 5 is 5. Subtract, we get 2. Bring down the 1. 5 goes into 21 4 times. 4 times 5 is 20. Subtract and get 1. Bring down the 5. 5 goes into 15 3 times. 3 times 5 is 15. Subtract and get 0. So 143 times 5. So 143 times 5. 5 is prime. 143 is not. It's 13 times 11. But 13 and 11 are each prime numbers. And then what about 247? Well, I really don't have a clue on this one. I don't really work with this number very often. I can start making some guesses. I can say 2 plus 4 is 6. 6 plus 7 is 13. Not divisible by 3. I know it's not divisible by 2. Not divisible by 5. What about 7? If I take and cut the 7 off, and then I double it, I get 14. 24 minus 14 is 10. Not divisible by 7. And if I take the square root of 247, I get about 15.71. So I've tested up to 7. I just need to test 11 and 13. So for 11, I would number this as 1, 2, and then 3. 2 plus 7 would give me 9. And then if I subtracted away 4, that would give me 5. So that's not divisible by 11. Let's go ahead and just divide this by 13 and see what happens. 13 will go into 24 once. 1 times 13 is 13. Subtract here. 4 minus 3 is 1. 2 minus 1 is 1. Bring down the 7. Now I have to ask, how many times will 13 go into 117? Well, 13 times 10 is 130. If I have 130 and I take 13 away, I get exactly 117. So that tells me this is 9. 9 times 13 is 117. Subtract here, we get 0. So 19 times 13. Now each number here is prime, so we're done finding the prime factorizations. All right, let's make a little table. So we want a table for 55, 715, and 247. And again, let's start out with the smallest prime factor. So when I look through it, I see that that's a 5. There's a 5 in the prime factorization of 55. There's a 5 in the prime factorization of 715. It's not in the prime factorization of 247, so we'll just kind of mark that off. We'll then look for the next prime factor. Looks like that's going to be 11. So that's in 55 and 715. So we have 11. But again, it's not matched over here. Then next we'd have a 13 in the prime factorization of 715 and also 247. So we'll have 13 here and here, but not here. And then lastly, we have a 19 in the prime factorization of 247. So we'll have times 19, but that's not matched here or here. So we'll cross these out. All right, so to build my LCM for 55, 715, and 247, again, each and every prime factor from the prime factorizations is going to go in. The only time we have to kind of change up what's going in is when we have something that's shared, in this case, since we have three numbers, by at least two of the prime factorizations. So when we look at 5, it's shared between two of them. So I put the largest number of repeats, and the largest number of repeats would just be 1. Right? It only occurs once here and once here, so we throw 1 5 in there. Then we look at 11. That's shared again, but the largest number of repeats, again, is just 1. So we put 1 in there. Then for 13, same situation. It's shared between two prime factorizations, but the largest number of repeats, again, is just 1. So we're going to put times 13. Just put 1 factor in there. And then lastly, we have 19. 19 is not shared with anything else, so we just throw it in there. We don't need to worry about how many times it goes in, because it's only going in once, not shared with anything. All right, so now we just multiply. 5 times 11 is 55. 55 times 13 is 715. Then if I multiply by 19, I get 13,585. And that's going to be our answer for the LCM of 55, 715, and 247. Hello and welcome to Pre-Algebra Test Section 1 on finding the least common multiple, and I have abbreviated here the LCM. So we want to find the LCM by listing the multiples of each number. So we're going to start out by finding the LCM of 4 and 10. So this is kind of a tedious method that we first covered in the lesson. And basically to generate the multiples of a number, you take the number, so for example with 4, we're going to take that number and we're going to multiply by each non-zero whole number. So you'd start out with the number 1. 4 times 1 would be 4. Then you'd multiply by 2. 4 times 2 would be 8. Then by 3, that would be 12. And you can notice here that you're just increasing in increments of 4. So after 12 would be 16, then 20, then 24, then 28, and so on and so forth. That's where we put the 3 dots there. Obviously, I can't list every multiple of 4, but the 3 dots will tell me that after 28 comes 32 and 36. Again, just increasing in increments of 4 out indefinitely. Now for 10, again, we're going to do the same thing. We'd start by multiplying by 1, so 10 times 1 is 10. Then by 2, so that would be 20. You're just increasing in increments of 10. So 30, then 40, then 50, then 60, then 70, then 80. And I'm going to put 3 dots to say, hey, we're going to increase in increments of 10 indefinitely. So now I'm looking between these two lists here, and I'm looking for common multiples, and more specifically, the least common multiple, or the multiple they have in common that has the least value. So kind of looking through here, I see that 20 appears in this list and also in this list. And that is the lowest number that I see. So that's going to be my least common multiple. Okay, so that's going to be 20 for 4 and 10. All right, let's do one more. Again, this method is very inefficient. We're just doing it so that you know both methods might come up on a test. All right, so we're going to list the multiples for 6 and 21 here. So for 6, again, start out by multiplying by 1. 6 times 1 is 6. And then just increase in increments of 6. So we'd have 12, then 18, then 24, then 30, 36, 42, 48, and I think that's enough. Now for 21, you'd start out with 21 times 1, so that's 21. Then times 2 would be 42. Then we'd have 63. 84, 105, 126, and we'll go ahead and stop there. So what is the least common multiple that we can find? Well, looking, I see that 42 occurs here, and it occurs here. So that's going to be our least common multiple. So for the LCM of 6 and 21, it's going to be 42. Hello, and welcome to Pre-Algebra Test Section 2 on finding the LCM. Again, that's the least common multiple. So for our problems, we just want to find the LCM. And we're going to start out with the LCM of 15 and 18. So basically, we just want to find the prime factorization for each number. And for 15, we basically know that that's 5 times 3. We don't really need a factor tree for that. And for 18, we know that's 9 times 2, and 9 is 3 times 3. So 2 times 3 times 3. The next thing we do is we build a table to kind of organize our numbers. So 15 and then 18. And basically what I'm going to do is I'm going to put the prime factorizations in here, but I'm going to line them up to where anything that's in common is going to be on top of each other. So I have a 2 in 18, but nothing in 15. I have a 3 in 15 and 18. And then I have a second 3 in 18, but not in 15. And then in 15 I have a 5, but it's not in 18. So I'm just going to X out all these. And we can see that basically we just have 1 3 that's common to both. Now when we build our LCM for 15 and 18, basically what we want to do is take each and every prime factor from all of these prime factorizations, we just have 2 here, and throw them in a list that we're going to make. And we're going to multiply the numbers on the list together. But there's a catch. If there's a prime factor in the prime factorizations that's shared, you only put in the largest number of repeats. So in this case, for 18, we have this prime factor of 2. It's not shared up here, so I just throw it in. For 15 and for 18, you have one prime factor of 3. For 18, you have a second prime factor of 3. So because you have something that's shared, right, that 3 is shared, you only put in the largest number of repeats for that number. So the largest number of repeats occurs in the prime factorization of 18, right? There's 2 factors of 3 there, only 1 factor of 3 in the prime factorization of 15. So I'm just going to put 2 in when I'm building my list. The common mistake would be to put 3 in there. And although that's going to give you a common multiple, it's not the least common multiple. And that's what we're looking for. Now the next number is 5. That's not matched anywhere, so we just throw that guy in there. So now we just multiply. 2 times 3 is 6. 6 times 3 is 18. 18 times 5 is going to give us 90. So the LCM for 15 and 18 is 90. All right, let's find the LCM for 14 and 63. So again, factor each number. 14 is 7 times 2. 63 is 7 times 9. And 9 is 3 times 3. So we can build a table, again, to help organize these numbers. So I've got a 2 in the prime factorization of 14. Don't have it in 63. I've got 2 3s in the prime factorization of 63. Don't have it in the prime factorization for 14. And then I've got a 7 in the prime factorization of 14 and also in 63. I'll go ahead and X these out. And you can see the only thing they really share is that 7 there. That's common to both. So when we build our LCM, for 14 and 63, again, we're putting everything in from all our prime factorizations. So I'm putting in a 2. I'm putting in a 3. I'm putting in a second 3. When I get to the 7, that's where I need to stop because that's something that's common to both. When you have a prime factor that's common to both, you put the largest number of repeats from either of the prime factorizations. In the prime factorization of 14, I have 1 factor of 7. In the prime factorization of 63, I have 1 factor of 7 as well. So the largest number of repeats is 1. So we just put 1 7 in when we're building our LCM, right? We don't put 2 in. We don't need it. All right, so now let's just multiply. 2 times 3 is 6. 6 times 3 is 18. And then 18 times 7 is 126. So that's going to be our LCM for 14 and 63. Hello and welcome to Pre-Algebra Test Section 3 on finding the LCM. Again, that's the least common multiple. So we want to find the LCM, and we're just working with one problem here. We're going to look for the LCM of 24, 81, and 156. So again, we're going to start by factoring each number. So 24, I don't think we need a factor tree for that. That's just 4 times 6. We know that 4 is 2 times 2, and 6 is 2 times 3. For 81, that's 9 times 9, and I know 9 is 3 times 3, so we can just put 3 times 3 times 3 times 3. And then for 156, I know that 56 is divisible by 4. So I know that 156 would be divisible by 4. Let's do that. 156 divided by 4. 4 we're going to 15 3 times. 3 times 4 is 12. Subtract and get 3. Bring down the 6. 4 goes into 36 9 times. 9 times 4 is 36. Subtract and get 0. So 39 times 4. 39 times 4. Now I know 4 is 2 times 2. And I know 39 is 13 times 3. Okay, so now that we have our prime factorizations, we're going to go through and make a nice little table for ourselves. So we have 24, we have 81, and we have 156. And this table is just going to help us organize our numbers. So what we want to do is just write out the prime factorizations for each number in a way to where we can see what's common to everything. So I'm going to start out with 2. That's the smallest prime factor from any of the factorizations. I've got 3 factors of 2 in 24. I've got no factors of 2 in 81. And I've got 2 factors of 2 in 156. So what I generally do is just kind of line everything out to show what's common and what's not. The next highest prime factor would be 3. I've got 1 in the prime factorization of 24. I've got 1 in the prime factorization of 156. And I've got 4 in the prime factorization of 81. So I'm going to go ahead and line these spaces out because it's not shared. And then lastly, I have a 13 in the prime factorization of 156. So I'll put that there. And again, that's not matched, so I'll kind of line that out. Okay, so now we can build our LCM. We're going to build it from this table here. So the LCM for 24, 81, and 156, what we want to do is we want to include each and every prime factor from all of the prime factorizations here. Now, the trick is when you have a prime factor that is common to, in this case we're working with 3 numbers, so you'd say common to at least 2 of them, you only include the largest number of repeats between any of the prime factorizations. So for example, with 24, you'll see that you have 1, 2, 3 factors of 2. No factors of 2 in 81, 2 factors of 2 in 156. Where a lot of students get confused is they'll go, okay, I have 1, 2, 3, 4, 5. So I'm going to put 5 factors of 2 in the prime factorization for the LCM. That's wrong. You use the largest number of repeats between any of the prime factorizations. So the largest number of repeats occurs here, where we have 3 factors of 2. 3 factors of 2 here, only 2 factors of 2 there. 3 factors of 2 is the largest number of repeats, so that's what we put in when we're building our LCM. Now the next number is 3, and you're going to see that that's common to everything. You have at least 1 3 everywhere, but the largest number of repeats occurs in the prime factorization of 81, so you're going to put 1, 2, 3, 4 factors of 3 in here. 1, 2, 3, 4. Again, the common mistake would be to put 1, 2, 3, 4, 5, 6 of them in the prime factorization for the LCM. You don't need that many, right? That's going to give you a common multiple, but it's going to be too big. It's not going to be the least common multiple. So again, you want to use the largest number of repeats that occurs in any of the prime factorizations when you have a number that's common to at least 2 of them, right? At least 2 of them. So now the next number is 13. And I can just throw that in there because it's only common to 1 of them. I don't need to look for the large number of repeats. It just occurs once in the prime factorization of 156. So once I have this list going, I just multiply everything together and I have my LCM. 2 times 2 times 2 is 8 times, we know that 3 times 3 times 3 times 3 is 81. So 8 times 81 would be 648. And then we multiply by 13, we'd get 8,424 as our answer. Hello and welcome to Pre-Algebra Test Section 4 on finding the LCM. Again, this is the least common multiple. So we want to find the LCM, and we're just working with one problem here. We want the LCM for 121, 165, and 231. So we're going to start by factoring each number. Let's do this down here. So for 121, I happen to know that that's 11 times 11. And 11 is a prime number, so let's circle both of those. The next number is 165. So let me just write that 121 is 11 times 11. And we're going to go down there and look at 165. So that's going to be divisible by 5 since it ends in a 5. So what's 165 divided by 5? 5 goes into 16 3 times. 3 times 5 is 15. Subtracting, you get 1, bring down the 5. 5 goes into 15 3 times. 3 times 5 is 15. Subtracting, get 0. So 5 times 33. 5 times 33. 5 is prime, and 33 is 3 times 11. 3 and 11 are both prime. So 3 times 5 times 11. And then what about 231? Well, 2 plus 3 is 5. 5 plus 1 is 6. So I know it's divisible by 3. Let's start out with that. 3 goes into 23 7 times. 7 times 3 is 21. Subtracting, you get 2. Bring down the 1. 3 goes into 21 7 times. 7 times 3 is 21. Subtracting, get 0. So 3 times 77. 3 is prime. 77 is 11 times 7. 7 and 11 are both prime. So 3 times 7 times 11. So 231, again, is 3 times 7 times 11. And now we're going to build ourselves a nice little table so we can organize our numbers. So for 121, 165, and 231. So what we do is we kind of write our prime factors in the table to where it's obvious what's common to everything. So I'm going to start with the smallest prime factor between any of the prime factorizations. That's a 3. And that's going to be in the prime factorization of 165 and 231, but not in 121. So I'm just going to kind of X that out. Next I have 5. That's in the prime factorization of 165. Not in 121, not in 231. So I'm just going to X those out. Next I have a 7 in the prime factorization of 231. And it's not common to 165 or 121. So we're just going to X those out. And lastly, we have 11. So I have 2 factors of 11 in 121. I have 1 factor of 11 in 165 and 1 factor of 11 in 231. So I'm just going to X those out here. And now we can build our LCM from the information in this table. So for the LCM of 121, 165, and 231, what we need to do is include each and every prime factor from all the prime factorizations. When you have one of your prime factors that occurs in more than one of the prime factorizations, so when you're working with 3 numbers, it's going to just be at least 2. You're going to include the largest number of repeats from any of the prime factorizations. So for example, if we start out with the number 3, if you look in the prime factorization of 165, you have 1 factor of 3. If you look at the prime factorization of 231, you have 1 factor of 3. So because this is common to these 2 prime factorizations, I want to use the largest number of repeats between any of the prime factorizations. It only occurs once here and once here, so I only put 1 in when I'm building my list for the LCM. I only want 1. The common mistake is to put 2 in. But again, use the largest number of repeats between the 2 factorizations there, and that's just 1. Now the next number is 5. Now that's only in the prime factorization of 165, so you just throw that in there. Then there's a 7. That only occurs in the prime factorization of 231, so just throw that in there. Next we have 11. Now you'll see that everything has at least one 11, but in the prime factorization of 121 you have 2 of them. So again, if you have something that's common, you need to only include the largest number of repeats between any of the prime factorizations. That's going to occur right here. You have 2 in the prime factorization of 121, so that's all you're going to put in here. Just 2 factors of 11. Again, the common mistake would be, okay, I'm going to put all of these in here. So I put 1, 2, 3, 4 factors of 11. You don't want to do that. Again, if something's common, put the largest number of repeats between all of your prime factorizations. Again, that occurs here. So we put 2 factors of 11 when we build our LCM. All right, so now we just want to multiply. 3 times 5 is 15. 15 times 7 is 105. Times 11 is 1,155. Times 11 again is going to be 12,705. And that's going to be our LCM for 121, 165, and 231. Hello and welcome to Pre-Algebra Test Section 5 on finding the LCM. Again, that's the least common multiple. So we want to find the LCM, and we just have one problem to work on. We want to find the LCM for 550, 150, and 225. So the first thing we're going to do is factor each number. So for 550, it ends in a 0, so I know it's divisible by 10. This will be 55 times 10. 55 is 5 times 11. 10 is 5 times 2. And all of these numbers are prime. So for 550, the prime factorization we'll write as 2 times 5 times 5 times 11. For 150, it also ends in a 0. So I could do 15 times 10. 15 is 5 times 3. 10 is 5 times 2. All of these are prime. So for 150, we have 2 times 3 times 5 times 5. Then for 225, that's 15 times 15. So I don't need a factor tree for that. That's just going to be 5 times 3 times 5 times 3. And I can write that as 3 times 3 times 5 times 5. Okay, so let's make a little table to organize our numbers here. So I'm going to put 150, 225, and then 550. So I'm looking for basically the smallest prime factor, and I'm going to write that in first. So the smallest prime factor is 2. So that occurs in the prime factorization of 150 and also in 550, but not in 225, right? Because this is an odd number. So I put those in, and then basically what I do is I'm just going to X this out here to say that it doesn't have it. I'm just looking for a way to kind of show what's common to everything. Now the next largest prime factor is 3. I've got one of them in the prime factorization of 150, and I've got 2 of them in the prime factorization of 225. So what I'm going to do is I'm going to X out these positions here where it's not common. All right, next I have 5, and everything has 2 factors of 5 in it. So I'm going to put 2 factors of 5 everywhere. And then after that I have 1 factor of 11 in 550. But it's not shared anywhere else, so we'll X that guy out. Okay, so from this table, we can now build our LCM. So building the LCM for 150, 225, and 550. Now sometimes it seems a little complicated, but essentially you just need to do this. You're including every prime factor from all the prime factorizations. It's just a matter of how many times you put it in when you build your LCM. So for example, if any prime factor is repeated between, in this case we have 3 numbers involved, so between at least 2 of them, all you need to do is include only the largest number of repeats between any of the prime factorizations. So for example, with the factor of 2, I only have 1 factor of 2 in the prime factorization of 150, and 1 factor of 2 in the prime factorization of 550. So I just put 1 factor of 2 in when I build my LCM. The common mistake is to throw 2 factors of 2. They say, okay, well, I got a 2 there and a 2 there, so I put 2 factors of 2 in. That's the wrong answer. Although it would give you a common multiple, it's not the least common multiple, so it's the wrong answer. So again, the largest number of repeats between any of the prime factorizations. The largest number of repeats is that it occurs only once, so only 1 goes in when we build our LCM. The next number is 3. So that's common here to 150 and 225. The largest number of repeats occurs in the prime factorization of 225. You have 2 factors there, so I put 2 factors in when I build my LCM. Again, don't put 3 of them in there, only use the largest number of repeats. The largest number of repeats is 2, so you get 2 factors in when you build the LCM. Next we have 5. Now everything has 2 factors of 5. So you guessed it, we're going to put 2 factors of 5 in here, and only 2 factors of 5, because again, you use the largest number of repeats when something is common. The largest number of repeats is 2. Everything has only 2 factors of 5, so again, that's all we're putting in there. Don't put 6 factors of 5 in when you build your LCM. The last number 11 is not common to anything else. It just occurs in the prime factorization of 550. So we just throw this in here and we're done. All we need to do now is just multiply the numbers together, and we'll have our LCM. So 2 times 3 is 6, times 3 is 18, times 5 is 90, times 5 is 450, then times 11 is 4,950, and this is going to be our LCM for 150, 225, and 550. Hello and welcome to Pre-Algebra Practice Set number 33. In this video, we're going to look at some additional practice problems for our lesson on adding and subtracting fractions. All right, so we're going to start out with 3/5 minus 1/5. So remember, when you add or subtract fractions, you have to have a common denominator. In this case, we have a common denominator of 5. So when we see that, we know that we're going to have an easy job. Basically, what we're going to do is we're going to rewrite that common denominator as the denominator for our answer. We don't need to touch the denominator again. We're done with that part. Then we're going to perform this operation using the numerators only. So I'm going to do 3 minus 1, and 3 minus 1 is 2. So I'm going to write that as my numerator. So the answer here is going to be 2/5. Now when you work with fractions, you always want to report your answer where it's simplified, or we could say reduced to its lowest terms. Now 2 and 5 are both prime numbers, so there's really nothing that we can cancel between the numerator and denominator. So this is going to be our simplified answer. Again, it's going to be 2/5. What about 7/9 plus 5/9? Again, we have a common denominator here, so we don't need to touch that. We're just going to use 9 as our denominator in the answer, and then we're just going to add the numerators, right? So we're going to do 7 plus 5, and that gives us 12. Now, if we look between 12 and 9, we should know that both are divisible by 3. So if the greatest common divisor, or again, the greatest common factor, it's the same thing, between the numerator and denominator is 3, you can divide each by 3 and get your simplified fraction. So 12 divided by 3 would give me 4. 9 divided by 3 would give me 3. So I end up with 4/3. And again, if you can't do that in your head yet, just go ahead and factor each number. So 12, you know, is 2 times 2 times 3. And 9 is 3 times 3. And then look to see what you can cancel between numerator and denominator. Well, you can only cancel one factor of 3. Again, that's the greatest common factor or the greatest common divisor. And you just go through and see what's left. I have 2 times 2 or 4 in the numerator over just a 3 in the denominator. So kind of either way you do that, you end up with 4/3 as your simplified answer. All right, let's take a look at -8/3 plus -7/3. So again, we have a common denominator of 3. So that's going to be our denominator in the answer. And then we're just going to add the numerators. What is -8 plus -7? Negative plus negative is negative. And then 8 plus 7 is 15. So we'd end up with -15/3. Now, the greatest common divisor here is going to be 3, right? Between 15 and 3. Just forget about that negative for a second. So I can just divide the numerator and denominator by 3. And we'd end up with -5 over 1, or just -5. And you should know that 15 divided by 3 is 5. So if I have -15 divided by 3, that's going to give me -5. Again, another way you can think about this, if I factor -15, just think about it as -1 times 5 times 3. 3 is a prime number, so we're not going to factor that. And then just cancel this common factor of 3 between numerator and denominator. Remember, if something cancels completely, you just put a 1. And we end up with -1 times 5, or -5 over 1, which would just be -5. Okay, now let's look at -1/8 minus -5/8. So the first thing I want you to notice is that you have minus a negative. Remember, when you have minus a negative, it's plus a positive. So let's write this as -1/8 plus, again, positive 5/8. So now that we got that out of the way, we have a common denominator of 8. So we're going to write that. And then we just perform the operation with the numerators. So what is -1 plus 5? Well, it's the same thing as saying what is 5 minus 1? And that's 4. So looking at 4 over 8, or 4/8, most of you can tell that the greatest common divisor is going to be 4. So if you divide each by 4, 4 divided by 4 is 1, 8 divided by 4 is 2, you'll end up with a simplified answer of 1/2. Again, if you can't do that, just take 4 and factor it. 4 is 2 times 2. 8 would be 2 times 2 times 2. And you can see that you can cancel a common factor of 4 between numerator and denominator. And again, you'd end up with 1/2 as your answer. All right, what about 9 over 50 minus 14 over 50? Again, we have a common denominator. So I'm just going to write that guy there. And we're just going to do 9 minus 14. So to do 9 minus 14, again, you can think about this as 9 plus negative 14. The sign is going to be negative. And then I would do 14 minus 9, and that's going to give me 5. So we'll end up with negative 5 as my answer there. So negative 5 over 50. Now forget about the negative for a minute. If I think about 5 and 50, the greatest common divisor is going to be 5. Right? So if I divide this by 5, I'd end up with a negative 1. If I divide this by 5, I'd end up with 10. So we'd end up with negative 1/10 as our answer. And again, you could just factor. You could leave this as negative 5. And then you could take 50 and say that's 5 times 5 times 2. Again, cancel this with this. That's going to give you a 1. And just work with what's left over. You'd have negative 1 over 5 times 2 or 10. Again, negative 1/10 is your answer. Okay, now we have one with 3 fractions. But again, it's easy because we have a common denominator for each. I'm just going to rewrite that 16 there and just add straight across. So 5 plus 11 is 16. 16 plus negative 4 is the same thing as 16 minus 4. So that's 12. So the greatest common divisor between 12 and 16 would be 4. Right? You can think about 12 as 4 times 3. And I know you could break it down further and say it's 2 times 2 times 3, but just think about it as 4 times 3. And think about 16 as 4 times 4. So again, greatest common divisor is 4. So 12 divided by 4 is 3. 16 divided by 4 is 4. So 3/4 would be your simplified answer. And again, I keep doing this. If you need to factor it further, just think about 12 as 2 times 2 times 3. Think about 16 as 2 times 2 times 2 times 2. And again, you can cancel a common factor of 4 between the numerator and denominator and be left with a 3 over a 2 times 2 or 4, which leads us to this right here, this 3/4. Again, if you notice the greatest common divisor is 4, then you can just divide each by that number and get your simplified fraction in a shorter period of time. Okay, what about negative 2/5 minus a negative 1/5 minus 7/5? So the first thing I'm going to do is rewrite this as negative 2/5. Minus a negative is plus a positive. So I'm going to put plus 1/5. And then I'm going to put minus 7/5. Now we have a common denominator of 5. So I'm going to put that as my denominator for the answer. And then I'm just going to add and subtract across. Remember, you just go left to right. So negative 2 plus 1 is negative 1. And then negative 1 minus 7 is the same thing as negative 1 plus negative 7. So that's negative 8. So we ended up with negative 8/5 as our answer. And there's nothing we can really cancel here. If you think about 8, it's 2 times 2 times 2. If you think about 5, it's a prime number. So we're going to stay with negative 8/5 as our answer. All right, let's take a look at some problems where we don't already have a common denominator. So these are more tricky, right? They require more work, and a lot of students will get a little bit confused when they're trying to find the least common denominator. So for 11/15 plus 12/40, again, the first thing we need to do is find a common denominator. Here I have 15, here I have 40. I can't just add and go, okay, 11 plus 12 is 23, over 15 plus 40, that's 55. Please don't make this mistake. This is wrong. Wrong. Okay, don't do that. The second mistake that students make is when they're finding a common denominator, they'll just multiply the two denominators together and say, okay, 15 times 40 is 600, so that's going to be my common denominator. You don't want to do that either because it's going to give you more work in the end, right, as far as simplification. So to find the least common denominator, abbreviated LCD, what we want is we want the least common multiple for 15 and 40. And again, in our previous lesson, we learned how to find the least common multiple. So I would just factor each number. 15 is 5 times 3. 40, I'm going to write as 5 times 8, or 5 times 2 times 2 times 2. When they have a factor in common, you use the largest number of repeats between any of the two factorizations. I have one factor of 5 here and one factor of 5 here, so the largest number of repeats is just 1. So I put one factor of 5 in, and then everything else goes in because it's not common to both. So I put a 3 in, and I put 3 2's in, so I basically put 8 in. So 5 times 3 is 15, and then 15 times 8 is 120. So again, the reason we use this least common denominator of 120, that's smaller than if I just multiplied 15 times 40 and got 600. So when I go to simplify, it's going to be less work. So now that we have found our least common denominator, we're going to transform each fraction into an equivalent fraction, meaning it has the same value, where 120 is the denominator. So how do we do that? So we have 11 over 15. We want to multiply the denominator by an amount that's going to change it to a denominator of 120. So 15 was 5 times 3, so to get to 120, I need to multiply by 8. Now the trick here is, if I multiply the denominator by 8, I need to also multiply the numerator by 8, because 8 over 8 is really 1, and multiplying by 1 leaves a number unchanged. Now the next thing I'm going to do is transform 12 over 40, again, into an equivalent fraction where 120 is the denominator. So 12 over 40 times, well, 40 is 5 times 8, so it's really needs to be multiplied by 3. So multiply this by 3, and then again, to make it legal, you multiply the numerator by 3. In each case, I'm basically multiplying by 1. It's a complicated form of 1, but it's really 1. So again, the LCD is 120, and I'm just going to continue this down here. Now, I got a lot of operations going on, but remember, the order of operations tells me to multiply before I add. So I'm going to figure these parts out first before I do any addition. So 11 times 8 is 88. We know that 15 times 8 is 120. 12 times 3 is 36. And again, we know 40 times 3 is 120. So now my common denominator is here, and I just write that. And I just need to perform the operation with the numerators. So what is 88 plus 36? 8 plus 6 is 14. 1 plus 8 is 9. 9 plus 3 is 12. So I'm going to get 124 over 120. Now I'm not done, because each number here is divisible by 4. I know that 20 is divisible by 4, the last two digits of that number. I know 24 is divisible by 4, the last two digits of that number. So 124 divided by 4 would be 31. So this would be 31, and 120 divided by 4 is going to give me 30. Now 31 is a prime number, and 30 is 5 times 6, or you could say 5 times 2 times 3, but there's nothing else I can cancel between numerator and denominator. So again, if you know your greatest common divisor, and I spotted that it was 4 right away, you can just divide each by that number and get to your simplified fraction. Again, the slower way would be to say, okay, 124 is 31 times 2 times 2. 120 is, 30 times 4. So 2 times 2 times 2 times 3 times 5. Then again, between numerator and denominator, you can see that I'm canceling 2 factors of 2, or a factor of 4. And I end up with 31 over 2 times 3, which is 6, times 5, which is 30. I just took a little shortcut. Okay, what about negative 1/3 plus 5/9? So a lot of you can, at this point, say that I know that the LCM between 3 and 9 would be 9, right? Because 9 is 2 factors of 3. 3 is a prime number. So the LCD is going to be 9. But let's formally do this. So the LCD is the LCM for 3 and then for 9. And again, 3 is not going to factor. It's a prime number. So again, because 9 has 2 3's in it, that's what we use in our LCM. So 3 times 3 is 9. So again, that's our LCD. So negative 1/3, I need to multiply by 3 over 3. And again, that's so I have a denominator of 9. And I multiply the numerator by 3 so that we have 3 over 3, which is a complicated form of 1. Multiplying by 1 leaves the number unchanged. Then plus, I have 5/9. Now, sometimes you're going to get a denominator that's already equal to the LCD. If this is the case, I don't need to do anything, right? I can leave this fraction alone. Now what I want to do is just perform this operation. Negative 1 times 3 is negative 3. Over 3 times 3, that's 9. And then plus 5/9. So I'll just continue this down here. So negative 3 plus 5 is the same thing as 5 minus 3. That's going to give me 2. And then it's over the common denominator of 9. So we end up with 2/9 as our answer. And 2 is a prime number. 9 is 3 times 3. So there's nothing we can really do to simplify this. So 2/9 is our simplified answer. Okay, let's take a look at 5 over 20 minus 4 over 30. So again, the LCD here, we're looking for the least common multiple for the two denominators. So 20 and 30. So factor 20, I know it's 5 times 4, 4 is 2 times 2. And 30 is 6 times 5, so 5 times 2 times 3. Each has one factor of 5, so one factor of 5 and only one factor of 5 goes in when I build my LCM. Each has 2 in the prime factorization, so we use the largest number of repeats, and that occurs here. So the largest number of repeats will be 2 factors of 2, so when I build the LCM, I'm putting 2 of those guys in there. And then we have a 3 in the prime factorization of 30. That's got to go in as well. So 5 times 2 is 10. 10 times 2 is 20. 20 times 3 is 60. So that's going to be my LCM for 20 and 30, and therefore my least common denominator that I can form. All right, so now we're going to transform these two fractions into equivalent fractions where 60 is the denominator. So if I have 5 over 20, so I need to multiply 20 by 3 to get to 60. Again, to make this legal, I do the same thing for numerator and denominator so that I'm really multiplying by a complicated form of 1. Then I have 4 over 30. So to get 30 to 60, I need to multiply by 2. So I'm going to multiply by 2 over 2, again, so that it's legal. Now let me erase all this and get some room going. So again, the LCD is 60, and I'm just going to continue down here. We're going to multiply 5 times 3, that's 15, over 20 times 3, that's 60. Then minus 4 times 2 is 8, over 30 times 2, that's 60. So now we're just going to subtract with our numerators. 15 minus 8 is 7, over the common denominator of 60. So we end up with 7 over 60 as our answer. And we can't do anything to simplify because 7 is a prime number. And 60 we know is 2 times 2 or 4 times 3, which would be 12, times 5, again, which would get me to 60. So nothing to cancel between numerator and denominator there. So this is already simplified. Okay, let's take a look at one final problem. And it's one with 4 fractions involved, so it's a little bit tedious, but I kept the denominators relatively small so that the work would be less. So we start out by finding, again, the least common denominator. And that's always going to be the least common multiple for your denominators. So you have 12, you have 14, you have 21, and you have 15. So factor 12, you get 4 times 3. And 4 is 2 times 2. Factor 14, you're going to get 2 times 7. Factor 21, you're going to get 3 times 7. And factor 15, you're going to get 3 times 5. So just kind of starting out with the lowest prime factor from any of these, we have a 2. The largest number of repeats occurs here, where you have 2 factors of 2, so that's what's going in here. Then next we move on to 3. This has 1, 3, this has 1, 3, and this has 1, 3. So we include 1, 3, and 1, 3 only. Then we have 1, 5 here, so that goes in. And then we have 1, 7 here, and 1, 7 here. So we put 1, 7 in only. So 2 times 2 is 4, times 3 is 12, times 5 is 60, times 7 is 420. So times 7 is 420. So now we're going to write each fraction as an equivalent fraction where 420 is the denominator. So we're going to start out with 4 over 12, or 4 twelfths, and we multiply that by what to get to 420? Well, this is what 12 is, so I need to multiply by 5 times 7, or 35, over 35. Then plus, we have 9 fourteenths, and 14 is 7 times 2, so I need to multiply by 2 times 3, or 6, times 5, or 30. So 30 over 30. Then minus, we have 6 over 21. And 21 is 7 times 3. So I'm multiplying by 5 times 2 times 2, or 5 times 2 is 10. 10 times 2 is 20. So 20 over 20. And then minus, we have 3 over 15. 15 is 5 times 3. So I need to multiply by 2 times 2, or 4, times 7, which is 28. So multiply by 28 over 28. All right, so 4 times 35 is 140. And we already know the denominator is going to be 420. Then plus 9 times 30 is 270. Again, the quick way to do that is 9 times 3 is 27. Put a 0 at the end. Over, we know that 14 times 30 is going to give us 420. Then minus 6 times 20 is 120. Again, 6 times 2 is 12. Put a 0 at the end. 21 times 20 is 420. Then minus, we have 3 times 28. That's 84 over 15 times 28, which again we know is 420. So now we just want to perform the operations working left to right. So let's start out with 140 plus 270. So 0 plus 0 is 0. 4 plus 7 is 11. Carry the 1. 1 plus 1 is 2. 2 plus 2 is 4. So that's 410. Now I'm going to subtract away 120. So I do 410 minus 120. So 0 minus 0 is 0. You need to borrow here. 11 minus 2 is 9. 3 minus 1 is 2. So that's 290. And then lastly, I'm subtracting away 84. Borrow here. 10 minus 4 is 6. 8 minus 8 is 0. Bring down the 2. So we get 206. And then over 420. So now we need to simplify. And both numbers are even, so for sure we can divide both by 2. So let's just do that and see what we get. 206 divided by 2 is 103. 420 divided by 2 is 210. Now the question you would ask yourself at this point, is 103 a prime number? If you took the square root of it, you get about 10.14. So I would test 2, which is not even, so it's not going to work there. 3, 1 plus 0 plus 3 is 4, so that's not going to work. 5 doesn't end in a 0 or 5, so that doesn't work. 7, if I cut 3 off and I double it, that would give me 6. Subtract it away from 10, that would give me 4. Not divisible by 7. And we can go ahead and test 11 too if we want. So number the digits here. This would be 1, 2, and 3. And again, it's just a coincidence that the first digit is a 1 and the third digit is a 3. But 1 plus 3 is 4. 4 minus 0 is 4. So it's not divisible by 11. So this number, 103, is a prime number. And so we have simplified this fraction as far as we can. So we end up with 103 over 210 as our final answer. Hello and welcome to Pre-Algebra Test Section 1 on adding and subtracting fractions. So for the problems we're going to look at today, we just want to find the LCD. Again, this means the least common denominator of the fractions. So we're going to start out with these two fractions here, 1/8 and 1/12. So I know a lot of you get confused when you start talking about LCD, LCM, GCF, GCD. Again, as you practice with these terms more and more, you'll not only understand what they are, but where and when to use them. So the LCD is found by finding the least common multiple, again abbreviated LCM, for the two denominators. So the least common multiple of 8 and 12 is what we're looking for here. So how do we find the least common multiple? Well, we'd factor each number. 8 is 4 times 2, 4 is 2 times 2, so we'd put 2 times 2 times 2. For 12, we'd put 4 times 3, or 2 times 2 times 3. Now when you build your LCM, essentially what you're doing is you're looking for factors that are common to the prime factorizations of all the numbers. In this case, you can see that 2 is common to both. Now when that occurs, you put the largest number of repeats from any of the prime factorizations. So in the prime factorization of 8, you can see you have 1, 2, 3 factors of 2. In the prime factorization of 12, you have 1, 2. So the largest number of repeats occurs here. So when I build my LCM, I'm putting 1, 2, 3 factors of 2 in there, because again, that's the largest number of repeats from any of the prime factorizations. Then the only other number we have is a 3. That's not common to both, so we just throw it in there. All right, so now we just multiply, and we'll have our least common multiple, and therefore have our least common denominator. So 2 times 2 is 4, 4 times 2 is 8, 8 times 3 is 24. So the LCD here, the least common denominator for these two fractions, 1/8 and 1/12, is going to be equal to 24. Let's take a look at another one. Let's say we had 2/3 and 5/18. So again, the LCD, or the least common denominator, is going to be the least common multiple of the two denominators. So 3 and then 18. But again, let's go through the process. So 3 doesn't factor, and 18 is basically 3 times 6, or 3 times 3 times 2. And so when you build your LCM, it's basically going to be 2 copies of 3, and 1 factor of 2, or just the number 18. So the LCD here is going to be 18. Okay, let's take a look at one final problem. So we have 2 over 14, 3 over 50, and 5 over 64. So again, to find the LCD, we're trying to find the LCM, the least common multiple, of 14, 50, and 64. So we're going to factor each number. 14 is easy, it's 2 times 7. 50 is easy, it's 25 times 2. So I'm going to put 2 times 5 times 5. And then 64 is 6 factors of 2. So 2 times 2 times 2 times 2 times 2 times 2. Right? You can just think about it as 8 times 8, right? Or 6 factors of 2. So when I build my LCM, the first factor, or the smallest prime factor in any of the prime factorizations, is 2. So 2 is common to everything. So again, I go with the largest number of repeats, and obviously that occurs here. So I'm going to put 6 factors of 2 in here, and I'm going to go ahead and just write that as 64. Just to save on space. Then the next thing I notice is I have 2 factors of 5. That's not common to anything else, so that just goes in there. And I have a factor of 7. That's not common to anything else, so that goes in there. So basically we have 64 times 25 times 25 times 7. So in the interest of time, I'm just going to do this multiplication with a calculator. 64 times 25 is 1,600. Then if we multiply by 7, we would get 11,200. So that's going to be your LCD. So your least common denominator is going to be equal to 11,200. Hello and welcome to Pre-Algebra Test Section 2 on adding and subtracting fractions. Alright, so for the problems, we're just going to perform the indicated operation. We're really just going to be doing some addition and subtraction. So we're going to start out with 4 25ths plus 6 25ths. So very important when you add or subtract fractions that you have a common denominator. In this case, we do have a common denominator to start, so it's a very simple problem. If you already have a common denominator, then your answer will have that common denominator. So in other words, I just take that 25 that's common to both and use it as the denominator for my answer. Don't make the mistake of adding 25 plus 25 and saying that, okay, this is going to be a denominator of 50. Right? The denominator is not going to change. The denominator will stay as a 25. Now I'm just going to add the numerators. So 4 plus 6 is 10, so I get 10 over 25. But we're not done. Whenever we work with fractions, we want to report our answer in simplified form, or as we'd say, reduced to its lowest terms. Now, at this point, you might be starting to get pretty good at this, and you might be able to eyeball that and say, okay, well, 10 is 5 times 2, and 25 is 5 times 5. So the greatest common divisor between the two, or the greatest common factor, it's the same thing, would be 5. So I can just divide each by 5. So divide 10 by 5, and I would get 2. Divide 25 by 5, and I would get 5. And I would have my simplified form for this fraction of 2/5. All right, let's take a look at 8 elevenths plus negative 4 elevenths. And again, we have a scenario where we have a common denominator. So that stays unchanged. We just write the denominator as 11, and we just perform the operation with the numerators. So I'd have an 8 plus a negative 4. That's the same as 8 minus 4, so that's 4. So if we have 4 over 11, that's already simplified. Right? 4 is 2 times 2. 11 is a prime number. So 4 over 11, or 4 elevenths, is our answer. Okay, now we look at 6 sevenths minus 5 sevenths. And again, we have a common denominator. So we're going to write that as the denominator in our answer. And then we just perform the operation with our numerators. So we do 6 minus 5, and that's 1. So we get 1/7 as our answer. So 1 can't be factored. It's not a prime number because it's excluded from that definition, but we can't really factor it. We can't do anything with it. 7 is a prime number, so we can't factor that either. We could do 7 times 1 if we want, but we really can't do anything. So 1/7 is as simple as we can make this fraction, so that's going to be our answer. Okay, for the last problem, we have 7 twelfths minus 4 twelfths. And again, we have another easy one where we have a common denominator already. So that's going to be the denominator for our answer. And then we just do 7 minus 4, and that's 3. Now, eyeballing this, I know that 12 is divisible by 3, right? Meaning 3 is a factor of 12, or 3 is a divisor of 12, however you want to think about that. So if I know that right away, I can divide each by 3. 3 divided by 3 is 1. 12 divided by 3 is 4. So again, that gives me a simplified fraction of 1/4. Again, that's kind of the quick way to do it. The slower way would be to say, okay, I have a 3 up here. 12 is 4 times 3. 4 is 2 times 2. And then just look between numerator and denominator and cancel here. Again, this is fine if you want to keep doing this. And a lot of times when you first start, it's probably better to do this so that you don't miss any common factors. But once you get good at it, you're going to speed up and do it this way, because on a lot of tests, you'll be timed and you won't have extra time to go through and do this. Hello and welcome to Pre-Algebra Test Section 3 on adding and subtracting fractions. So we just want to perform the indicated operation. And again, we're just going to be adding and subtracting some fractions. So we're going to start out with 3/7 plus 1/7 plus 2/7. So again, if you've watched all the videos up to this point, you know that when you add or subtract fractions, you have to have a common denominator. In this case, we already have one, and that's a denominator of 7. So for our answer, we have a denominator of 7. We just copy that common denominator. We don't mess with anything. We're done with that part. Now what we do is we perform the operation using our numerators. So we have 3 plus 1, that's 4. Then 4 plus 2, that's 6. So we get 6/7 as our answer. Now we always want to report our answer as a fraction that is simplified or reduced to its lowest terms. Now in this case, 7 is a prime number, and 6 is 2 times 3. So there's not really anything we can do to simplify this further. So 6/7 is our answer. All right, now we're going to look at 9/2 minus 3/2 minus 11/2. So again, we have a common denominator of 2. So when we look at our answer, we'll just put a denominator of 2, and then we'll just perform the operations using the numerators. So we'd start out with 9 minus 3, that's 6. Then we'd subtract away 11. So at this point, you might already know that 6 minus 11 is -5. But again, you can convert it and say, okay, 6 minus 11 is the same thing as 6 plus -11. We use the sign from the number with the larger absolute value. So we're going to have a negative here. And then we just do 11 minus 6, and that's 5. So we'd get -5 as our answer there. So once we've written it up here, we've got a -5 over a 2. So that's -5/2. And again, we're looking to simplify. Well, 5 is a prime number, and so is 2. So there's nothing we can really do. This is as simple as it's going to get. So our answer here is just -5/2. All right, let's take a look at 4/5 plus 3/5 minus 8/5 minus 7/5. So again, we have a common denominator of 5. So when we write our answer, the denominator will be 5. Now we just go through and perform the operations with the numerators, and we work left to right. Remember your order of operations, we work left to right with addition and subtraction. So we do 4 plus 3, that's 7. Then 7 minus 8. 7 minus 8, you can think of as 7 plus -8. Of course, the answer would be negative. And you would do 8 minus 7, that's 1. So you get -1. Then we're subtracting away 7 from that. So you can think of that as -1 plus a -7. Negative plus negative is negative. 1 plus 7 is 8. So we get -8 there. And our answer would be -8/5. Now again, we always want to look to simplify. Forget about the negative. 8 is 2 times 2 times 2. 5 is a prime number. So nothing we can cancel between numerator and denominator. And our simplified answer is -8/5. Hello and welcome to Pre-Algebra Test Section 4 on adding and subtracting fractions. So we just want to perform the indicated operation. And we're just going to be adding and subtracting here. So we're going to start out with 2/18 plus 5/20. Now, again, you already know, if you've watched all the videos so far, that if you add or subtract fractions, you have to have a common denominator. So here we have a denominator of 18. Here we have a denominator of 20. So before we can actually add, we have to change each fraction into an equivalent fraction, meaning it has the same value, but with a common denominator. So in order to do that, we find the least common denominator for these two fractions. So the least common denominator, which we abbreviate LCD, is going to be equal to the least common multiple, which we abbreviate LCM, of 18 and 20. So how do we find the LCM of 18 and 20? Well, we start by factoring each number. So 18 is going to be what? 9 times 2, 9 is 3 times 3. So 3 times 3 times 2. For 20, think about that as 4 times 5. 4 is 2 times 2. So 2 times 2 times 5. So we build the LCM from the prime factorizations. Basically, every prime factor from every prime factorization is going to go in. It's just when you have something that's common to both, you're only going to put in the largest number of repeats between those prime factorizations. So for example, with the number 2, I have one factor here and then 2 factors here. So because it's common to both, I use the largest number of repeats between either prime factorization. So I'm going to go with 2 factors of 2 because that's the largest number of repeats. So 2 times 2 here. The next I have 3 times 3. It's not common to both, so I just put 2 factors of 3 in. Then I have a 5. That's not common to both, so I just put 1 factor of 5 in. So now all I have to do is multiply, and I'll have my LCM. 2 times 2 is 4. 4 times 3 is 12. 12 times 3 is 36. Then 36 times 5 is 180. So once we've found the least common denominator, what we do is we rewrite each fraction as an equivalent fraction where 180 is its denominator. So if I look at 2 over 18, I know that if I multiply 18 by 10, I would get to 180. 18 times 1 is 18, then put a 0 at the end, you get to 180. So I'd multiply this denominator by 10. But again, to make this legal, I got to multiply the numerator by 10 as well. Remember, when we multiply by 10 over 10, we're basically multiplying by a complicated form of 1. 10 over 10 is 1. Multiply by 1, you leave the number unchanged. Now I'm going to do the same thing with 5 over 20. How do I go from 20 to 180? Well, I need to multiply by 9, right? 20 times 9, 2 times 9 is 18. Put a 0 at the end. So to make it legal, I multiply the numerator by 9 and the denominator by 9. And I'm just going to continue this down here. And let me just kind of erase this, make it a little easier for us to follow. So I'm going to put the LCD as 180, and I'm going to continue this down here. So I would multiply, 2 times 10 is 20. 18 times 10, we know that's 180. Then plus, 5 times 9 is 45. Over 20 times 9, I know that's 180. So now that I have a common denominator, my operation is relatively simple. I just use the common denominator as the denominator for my answer, and I just add the numerators. So we do 20 plus 45, and that's 65. But we're not done, because whenever we work with fractions, we always want to report our answer as a simplified fraction, or a fraction that's reduced to its lowest terms. So we would think about what is the greatest common divisor between 65 and 180. And for 65 and 180, they're kind of big enough to where I would want to factor the numbers to make sure that I got the right answer. 65 is 13 times 5. And for 180, let's just go ahead and write this as 36 times 5. And I know 36 can be further broken down, but we can see that 13 is a prime number, and 36 is not divisible by 13, so really we can stop here. Right? We can only cancel out a common factor of 5, meaning the greatest common divisor, or the greatest common factor, for these two numbers would be 5. So I'm left with my simplified result, a 13 in the numerator and a 36 in the denominator. So 13 over 36 is going to be my simplified answer. Okay, next let's look at 3 over 38 minus 2 over 133. So again, if we don't have a common denominator to start, we're looking for the least common denominator, and that's the lowest common multiple, or the least common multiple, between 38 and 133. So 38 would factor into 19 times 2. 19 is prime, and so is 2. For 133, I know we don't work with that number very often, but basically it's 19 times 7. Okay, so to build our LCM, again, everything goes in there, but when you have a factor that's common to both prime factorizations, you use the largest number of repeats. So I'm going to have a 2 times a 7 times only 119. Okay, don't put both of them in there, because the largest number of repeats, in each case, we only have one factor of 19, so I'm going to put 1 when I build my LCM. So what is 2 times 7? That's 14. Then times 19, that's going to be 266. Now we'll just rewrite each fraction as an equivalent fraction where 266 is the denominator. So we have 3 over 38. And remember, 38 is 19 times 2. So to get to 266, I just need to multiply by 7. And I'm going to do that in the numerator as well. Right? So I multiply by 7 over 7 so that it's legal. Right? I'm multiplying by a complicated form of 1. Then minus, I have 2 over 133. And 133 was 19 times 7. So what I need to do is multiply this by 2 over 2. Right? That would give me a denominator of 266. So again, let's continue this down here. And I'm going to just kind of erase this and put 266 here. And we'll multiply. 3 times 7 is 21 over, again, a denominator of 266. Then minus 2 times 2 is 4 over a denominator of 266. So 21 minus 4 is 17. And this is over 266. So again, we always want to report our answer as simplified. We know that 17 is prime, and we know the prime factorization of 266 is 2 times 7 times 19. So we don't have a 17 in there, so there's nothing we can do to further simplify this fraction. So 17 over 266 is going to be our simplified answer. Hello and welcome to Pre-Algebra Test Section 5 on adding and subtracting fractions. So we just want to perform the indicated operation, and we just have one problem. We're going to do 5 over 12 plus 4 over 21 plus negative 6 over 24. So again, when we add or subtract fractions, we have to have a common denominator to do that. So if we start out and we don't have a common denominator, we're first going to find the least common denominator, abbreviated as LCD, and this is equal to the least common multiple, abbreviated LCM, of your denominators. So we want the least common multiple of 12, 21, and 24. So we would factor each number to start. So 12 is 4 times 3, or 2 times 2 times 3. 21 is 7 times 3. 24 is 6 times 4, or we can think of that as 2 times 2 times 3 times 2. Now when I build my LCM, I'm putting every prime factor in for the prime factorization of the LCM. The only stipulation is if I have something that's common to, in this case, at least 2 of the prime factorizations, what I'm going to do is I'm only going to put the largest number of repeats from any of the prime factorizations in there. So for example, if I look at the prime factorization of 12, I see I have 2 factors of 2. If I look at the prime factorization of 24, I see I have 3 factors of 2. So I'm going to put 3 factors of 2 in when I build my LCM. Some common mistakes would be to put 5 factors of 2 in there. You don't need that many. You would only put the largest number of repeats between the prime factorizations. So since this one has 2 factors of 2 and this one has 3 factors of 2, you go with 3 factors of 2 because that's the largest number of repeats. Next we have the number 3. 3 occurs here, here, and here. Now the most times it occurs is just once. So we're just going to put 1 factor of 3 in when we build our LCM. Again, if it's common to at least 2 of them, just use the largest number of repeats. Then lastly we have this 7. The 7 is not common to anything, it's just in the prime factorization of 21. So we would just throw that guy in there. And now we just multiply. 2 times 2 is 4, 4 times 2 is 8, 8 times 3 is 24, 24 times 7 is going to give us 168. So now that we know that our least common denominator is 168, what we're going to do is we're going to transform each fraction into an equivalent fraction where 168 is the denominator. So the way we do this, let's say we start with 5 over 12. If we just think about what do I need to multiply 12 by to get to 168? Well, if you look at the prime factorization for 168, and you just kind of circle, okay, this is 2 times 2 times 3, that would give me 12. So what's left in here? I'd need 7 times 2 or 14. So if I multiply 12 times 14, I'd get to 168. Now, because I do this to the denominator, I have to do it to the numerator to make it legal. 14 over 14 is 1. If I multiply by 1, the number is unchanged. Next, we're adding we have a 4 over a 21. Again, what do I need to multiply 21 by to get to 168? So if you look at 21, it's 7 times 3. So what I'd be missing is 2 times 2 times 2, or 8. So multiply this by 8 over 8, and your denominator will be 168. Then lastly, I have a negative 6 over a 24. If you look at 24, it's basically 8 times 3. So 2 times 2 times 2 times 3. So essentially, I need to multiply by 7 over 7, so that my denominator will be 168. So 5 times 14 is 70. We know that 12 times 14 is 168. Plus 4 times 8 is 32. 21 times 8, we know that's going to be 168. Plus negative 6 times 7 is negative 42. Over 24 times 7, that's 168. And now we just add. So 70 plus 32. 0 plus 2 is 2. 7 plus 3 is 10. So I'd have 102. And I'm adding to that a negative 42. So the sign's going to be positive. And we just want to subtract 102 minus 42. 2 minus 2 is 0. And basically you'd have 10 minus 4, that's 6. So you'd have a positive 60 as your numerator. And then the denominator just stays the same, right? It's the common denominator here of 168. Now, we're not done because we always want to simplify our fraction, and both numbers here are even. So at minimum, they're divisible by 2. Now, I happen to know that 60 is divisible by 4, right? 60 divided by 4 is 15. So let's write 60 as 5 times 3, or 15, times 2 times 2, or times 4. And this is over 168 divided by 4 is 42. And again, kind of a quick way, if you look back at your scratch paper, you can see that if you had 2 times 2 here and you kind of box that off, what would be left is 2 times 3, that's 6, times 7 is 42. So you'd basically have 2 times 2 times 2 times 3 times 7. So now you can look and see what you can cancel between numerator and denominator. You can cancel 2 factors of 2 in the numerator with 2 factors of 2 in the denominator, basically canceling out a factor of 4. And then you can cancel out this factor of 3 from the numerator and denominator. So your greatest common divisor, or the greatest common factor between these two numbers, is 4 times 3, or 12. So if you knew that, you could divide 60 by 12 and get 5. And you could divide 168 by 12 and get 14. This works too, right? We canceled everything out and figured out that we get a 5 left in the numerator over 2 times 7, or 14 in the denominator. So we have 5/14 as our simplified answer. Hello and welcome to Pre-Algebra Practice Set number 34. In this video, we're going to look at some additional practice problems for our lesson on comparing fractions. Okay, so we just want to determine the rank of each fraction. So we basically just want to figure out what's the biggest, what's the smallest, so on and so forth. So let's start out with 4/9 and 3/8. So the first thing we're going to do is cross multiply here. And what that means is that we're going to take the denominator from this fraction and multiply it by the numerator of this fraction. So 9 times 3 is 27. So I'm just going to write 27 next to this fraction here. Then I'm going to do the same thing with this fraction. I'm going to multiply 8, the denominator of this fraction, by 4, which is the numerator of this fraction. So 8 times 4 is 32. So this number right here is going to correspond to this fraction right here. So let me just highlight this. I'm going to highlight this in blue and this in blue. And then I'm going to highlight this in yellow and this in yellow. So all we're looking for is the bigger number to tell us which fraction is larger. 32 corresponds to the 4/9. That's bigger than 27, which corresponds to 3/8. So we know that 4/9 is the bigger fraction. It's really that simple, right? So 4/9 is greater than 3/8. If you didn't watch the lesson, you might be scratching your head saying, hey, why in the world does that work? Well, let me kind of show you something real quick. If we have 4/9 and we have 3/8, kind of the slow, tedious way to do this would be to convert each fraction into an equivalent fraction where the denominator is the same. So generally, we'll transform these two fractions into equivalent fractions where the LCD is their denominator. But really, you don't even have to do that. Any common denominator you can find will work. And kind of the quickest common denominator to find is to use the product of the two denominators. So 9 times 8 is 72. That would kind of be the quickest common denominator you would find. In this case, it happens to be the least common denominator as well. So in order to get 72 as my denominator, I would multiply this fraction top and bottom by the denominator of the other fraction, so 8 over 8. I would multiply this fraction, top and bottom, by the denominator of the other fraction, so 9 over 9. So 4 times 8 is 32. 9 times 8 is 72. 3 times 9 is 27. 8 times 9 again is 72. So now we saw these numbers before. We saw 32 up here that corresponded to 4/9, and you can see that you have that 32 next to the 4/9. We saw 27 next to 3/8, and you can see that still corresponds here. Basically, we got the information we needed without going through all this. By taking this denominator from the other fraction and multiplying it by the numerator, I find out what the numerator would have been if I went through this process. And same goes for here. I find out what the numerator would have been if I go through this process. So it's a shortcut to kind of say, okay, 32 over 72 is larger than 27 over 72. So the one with 32 over 72, or from 4/9, is going to be larger. Right? We've just shortcutted the process, and we're only looking at the numerator because we know the denominators would be the same. All right, so let's look at 15 over 22 and 3/4. So 15 over 22 and 3/4. And again, all we need to do is cross multiply. 22 times 3 is 66. 4 times 15 is 60. 66 is a bigger number, so that tells me that 3/4 is a greater fraction. So we can put that 15 over 22 is less than 3/4. What about 5/18 and 6 over 21? Again, we cross multiply. 18 times 6 is 108. 21 times 5 is 105. So 108 is the larger number, so that tells me 6 over 21 is the larger fraction. So 5/18 is going to be less than 6 over 21. What about 3 over 45 and 1 over 15? So 3 over 45, and we have 1 over 15. So 45 times 1 is 45. 15 times 3 is 45. So we've come to the scenario where we found fractions that are equivalent, or basically they have the exact same value. If I have 3 over 45, and I divide the numerator and denominator by the greatest common divisor of 3, 3 divided by 3 is 1, 45 divided by 3 is 15, I see that I do in fact get 1 over 15. So these fractions have the same value, they just look different. So 3 over 45 is equal to 1 over 15. What about 5 over 6 and 14 over 24? Again, we cross multiply. 6 times 14 is 84. 24 times 5 is 120. Obviously, 120 is bigger than 84, so 5/6 is the greater fraction. 5/6 is greater than 14 over 24. All right, let's look at one final problem where 3 fractions are involved. So I would start by just comparing any 2 fractions. Doesn't really matter which ones you start with. So 5/9 and 12/17. 9 times 12 is 108. 17 times 5 is 85. So we know 12/17 is larger than 5/9. So now let's compare 5/9 and 8/15. So 9 times 8 is 72. 15 times 5 is 75. So 5/9 is greater than 8/15. So if 5/9 is smaller than 12/17, but it's larger than 8/15, then we know that 8/15 is the smallest number. So we can just go ahead and write greater than 8/15 here. Because again, if 8/15 is smaller than 5/9 and 5/9 is smaller than 12/17, it tells me that 8/15 is smaller than 12/17. So kind of looking at this, 12/17 is the largest, and it's greater than 5/9, which is smaller than 12/17, but greater than 8/15. And 8/15 again is smaller than both 5/9 and 12/17. Hello and welcome to Pre-Algebra Test Section 1 on comparing fractions. So we want to replace each question mark with the less than, greater than, or equals to. So we're going to start out with 4/5 question mark 8/10. So in the lesson, I kind of gave you a shortcut to do this. I told you that you can take the denominator of one fraction, which in this case for 4/5 is 5, and you can multiply by the numerator of the other fraction. So 5 times 8 will give me 40, and I just write that right next to that fraction. and I do it to the other one. So the denominator of this fraction is 10, multiplied by the numerator of this fraction, that's 4. 10 times 4 is 40. Now I just compare the two numbers, and basically, in this case, we have 40, and we also have 40, so we know the two fractions are equal in value. So we'd say 4/5 is equal to 8/10. You can kind of eyeball these fractions and see they're the same. If I took 4/5 and multiplied it by 2/2, I would end up with 8/10, right? So it's the exact same fraction. This one is just simplified. Now, if you don't understand why this works, I kind of, again, explained this in the lesson. What we're doing here is we're just using a little shortcut. If I had 4/5 and I had 8/10, generally the method you're going to use is you're going to rewrite the fractions as equivalent fractions where you have a common denominator, and then you're going to look to see which numerator is bigger to tell you which fraction is bigger. Now, when you do these type of problems, you don't always look for the LCD. Usually it's a little quicker if you just say, okay, I can get a common denominator by just taking the denominator of one fraction and multiplying it by the denominator of the other fraction. 5 times 10 is 50. So my common denominator, not my least common denominator, but just a common denominator, could be 50. So all I would do is multiply the numerator and denominator here by the denominator of the other fraction. So I'd multiply this by 10/10, and I'd multiply this by 5/5. And in each case, I'm going to get this common denominator of 50. So once I do 4 times 10, I'm going to get 40. That's what I did here, right? 10 times 4. I just kind of did it in a different way. Once I do 8 times 5, I'm going to get 40. That's what I did here. 5 times 8, I got 40. So essentially, I'm shortcutting this process here with this cross multiplication. I don't really need to know what the new denominator is going to be. I just know that they're going to be the same. So I can kind of skip all this and just cross multiply. I know that to get the new numerator, I'm going to be multiplying by the denominator of this fraction, right? This times this will give me the new numerator for this fraction. This times this will give me the new numerator for that fraction. So that's kind of why that shortcut works. All right, let's look at 2/3 4/7. Again, what we're doing is we're cross multiplying. So we're going to take this denominator, multiply by this numerator. 3 times 4 is 12. Then I'm going to take this denominator, which is 7, multiplied by this numerator, which is 2. 7 times 2 is 14. So 14 is larger than 12, so that tells me 2/3 is the bigger fraction. So 2/3 is greater than 4/7. And again, if I don't went through the long process of multiplying 2/3 by the denominator of the other fraction, 7/7, I would end up with 2 times 7, which is 14. Again, that's what I got there. And then 3 times 7 would be 21. So this would be 14/21. If I multiplied 4/7 times the denominator of this fraction, 3, so 3/3. 4 times 3 is 12. Again, that's what I got there. So 12/21. Again, the denominator is going to be the same. So I only need to think about what the numerator would be. So that's why we cross multiply and say, okay, the numerator would be 14 here, and the numerator over here would be 12. 14 is greater than 12, and so 2/3 is going to be the greater fraction. All right, what about 3/11 3/7? So again, we're just going to cross multiply. So 11 times 3 is 33, and 7 times 3 is 21. 33 is larger, so that means 3/11 is the smaller fraction. So 3/11 is less than 3/7. Again, if you went through and you multiplied 3/11 by 7/7, right? The denominator from the other fraction is 7. 3 times 7 will give you 21, right? So the new numerator for 3/11 would be 21. Now, the denominator would be 77. But again, because we know the denominator is the same, we don't really care what it is. We're only going to be looking at what the new numerator would be. For this one, 3/7, we'd be multiplying by 11/11. So 3 times 11 is 33. 7 times 11 again is 77. And again, if you look at these two fractions, they have the same denominator. This numerator is bigger, so it's the bigger fraction. Now, another thing you could think about here, without even cross multiplying, you can look at these two fractions here. Since they have the exact same numerator, the rule is if you have the same numerator and a bigger denominator, you have a smaller fraction. So 3 divided by 11 is going to give you a smaller number than 3 divided by only 7. as we divide by larger and larger numbers, our result gets smaller and smaller. I'm taking the same amount and cutting it up into more pieces, and so I get a smaller value as a result. Hello and welcome to Pre-Algebra Test Section 2 on comparing fractions. All right, so we just want to replace each question mark with the less than, greater than, or equal to. So we start out with 31 over 50, question mark 12 over 21. So the quickest way to compare these two fractions is to cross multiply. So we're going to take the denominator from this fraction and multiply it by the numerator of this fraction. So what is 50 times 12? Well, we have a trailing zero here, so I can do 5 times 12, that's 60, and then just put a zero at the end of that, so that would be 600. Then next we want to do 21, the denominator of this fraction, times 31, the numerator of the other fraction. So what is 21 times 31? Let's just crank that out real quick. 1 times 31 is 31. 2 times 1 is 2. 2 times 3 is 6. Bring down the 1. 3 plus 2 is 5. Bring down the 6. So this is 651 over here. So whichever fraction has the bigger number next to it is the larger fraction. So 651 is bigger than 600. So that tells us that 31 over 50 is greater than 12 over 21. What about 9/8, question mark 14/11? So again, we're going to cross multiply. We're going to take 8 and multiply it by 14. That's going to give us 112. And then we're going to take 11 and multiply it by 9. And that's going to give us 99. So 112 is the bigger number. So 14 over 11 is the larger fraction. So we're going to say that 9/8 is less than 14 over 11. Or again, 14/11. Hello and welcome to Pre-Algebra Test Section 3 on comparing fractions. So we want to replace each question mark with the less than, greater than, or equal to sign. So we start out with -4/15, question mark -2/7. So when you start comparing negative fractions, you have to think about the fractions in terms of their absolute value first. So just pretend that these numbers are positive. So let's say we had 4/15 and we had 2/7. So to find out which one is bigger, we would cross multiply. We would take the denominator of this fraction and we multiply by the numerator of this fraction. So 15 times 2 would give me 30. Then I multiply the denominator of this fraction, 7, times the numerator of this fraction, 4. 7 times 4 is 28. Now I know that this is the bigger fraction because 30 is a bigger number. So 2/7 is larger. So let's just go ahead and write that 4/15 is less than 2/7. Now, a lot of you might jump in and say, okay, well, -4/15 is less than -2/7. That would be wrong, right? This would be wrong. Here's why. When you work with negatives, the bigger the negative, the smaller the number. So if I had something like, let's say, 3 and 7, the relationship would start out like this. 3 is less than 7. But if I made these numbers negative, if I had -3 and -7, the reverse would be true. -3 is now a greater number, right? -3 would be greater than -7 because it's a smaller negative. Again, as we look at a number line, as we go to the left and these negatives get bigger and bigger, your values are actually becoming smaller. So for this example, since 4/15 is smaller than 2/7, when we make these numbers negative, -4/15 is going to be larger than -2/7 because this is going to be a smaller negative and therefore a larger number. All right, let's take a look at another one. We have -7/11 and -5/8. And again, what I'm going to do is pretend these numbers are positive. So we have 7/11 and 5/8. We'll cross multiply. 11 times 5 is 55. 8 times 7 is 56. So this is the bigger fraction, 7/11. So 7/11 is greater than 5/8. But again, when you start talking about them being negatives, the reverse is going to be true. So -7/11 is going to be a smaller number because, again, it's going to be a bigger negative. So this is less than -5/8. Hello and welcome to Pre-Algebra Test Section 4 on comparing fractions. All right, so we just want to arrange each group from smallest to largest using inequality symbols. So we have the fractions 4/5, 11/15, and 5/7. So we can start by just comparing any two fractions that we want. Let's start with 4/5 and 11/15. So I'm going to cross multiply. 5 times 11 is 55. 15 times 4 is 60. So that tells me that 4/5 is the larger fraction. So 4/5 is greater than 11/15. So let me then compare 11/15 and 5/7. So 11/15 and 5/7. So 15 times 5 is 75. And 7 times 11 is going to be 77. So 11/15 is going to be the bigger fraction. So 11/15 is bigger than 5/7. So if I know 11/15 is smaller than 4/5, and if I know it's bigger than 5/7, then I know 5/7 is the smallest one. I know 11/15 is the middle one, and I know 4/5 is the largest one. Now it told us in the directions that we wanted to arrange each group from smallest to largest using inequality symbols. We don't have that here. We have largest to smallest. So we just need to flip it around and say that 5/7 is less than 11/15, which is less than 4/5. Hello and welcome to Pre-Algebra Test Section 5 on comparing fractions. All right, so we want to arrange each group from smallest to largest using inequality symbols. So for the group, we have 2/3, 8/21, 4/7, and 3/5. Now, in some examples, you might see me comparing two fractions at a time until we kind of figure out the relative size of each fraction. I think when you have more than 3, it's probably quicker just to figure out what the LCD is and then change each fraction into an equivalent fraction where the LCD is its denominator. Once we have the same denominator in each case, we can just look at the numerators and see which fraction is the largest, the second largest, the third largest, and then the smallest. Let's go ahead and just get the LCD. So we have the denominators of 3, 21, 7, and 5. So the LCD, remember, is the least common multiple of the denominators. So for 3, 21, 7, and 5. So 3 doesn't factor, so we'll just put it in there. 21 is 7 times 3. I already have a 3, so I just put times 7. 7 is already in there, it doesn't factor. And then I'll just throw in a 5. So 3 times 7 is 21. 21 times 5 is 105. So for 2/3, I would multiply by 7 times 5, or 35, over 35, so that I can have a denominator of 105. But again, kind of, if you think back to the cross-multiplying shortcut, I don't need to know what the denominator is going to be, because I know in each case I'm going to get a denominator of 105. So save yourself a step and just say, okay, what is 2 times 35? That's 70. So I'm just going to write a 70 next to this fraction, because if I converted it into an equivalent fraction with 105 as denominator, 70 would be its numerator. All right, for the next one, I have 8/21. 8/21. So I would multiply that. If I had 7 times 3 is 21, I'd multiply it by 5/5. So again, just multiply the numerator by 5. 8 times 5 is 40. I'm going to write that next to that number right there. Then for 4/7, if the denominator is 7, I'd need to multiply by 3 times 5, or 15. So this would get multiplied by 15/15. Again, to save myself a step, I'm just going to multiply the numerator. 4 times 15 is 60. And then lastly, I have 3/5. 3/5. So that 5 there, I just need to multiply by 21/21. Again, save myself a step. 3 times 21 is 63. So now if I look at these fractions here, I can see that if I had changed them into equivalent fractions where 105 is the denominator, I'd have 70/105, I'd have 40/105, I'd have 60/105, and I'd have 63/105. And once I have the same denominator, it's very easy to see the relative size of the fractions. I know that this one is the largest. I know that this one is the smallest. I know that this one is the kind of second largest, And then this would be kind of the third largest, or you could say the second smallest. I don't know, third largest. So if we kind of ordered them 1 through 4, with 1 being the largest, this would be 1, this would be 2, this would be 3, and this would be 4. Now, if we look back at our instructions, it says arrange each group from smallest to largest using inequality symbols. So your smallest fraction here, again, if you look at the numbers, the fourth fraction is the smallest one. So that's 40 over 105, or the original fraction that we started with, 8 over 21. And that's going to be less than, if you look at the number 3, we have 60 over 105, which the original fraction was 4/7. That's going to be less than. Then we look at number 2, we have 63 over 105. The original fraction there was 3/5. And then kind of the largest fraction, the number 1, we have 70 over 105. And again, the original fraction was 2/3. And when you look at inequalities this way, everything has to work. So this has to be the smallest fraction because it's less than everything, right? 8 over 21 is less than 4/7, which is less than 3/5, which is less than 2/3. So this has to be the smallest. Then this 4/7 has to be greater than 8 over 21, but less than 3/5 and 2/3, and it is. 3/5 has to be greater than 4/7 and 8 over 21, but less than 2/3. That works. And then 2/3 has to be greater than 3/5, 4/7, and 8 over 21. And of course it is. So kind of our answer here, based on our instructions, is to write that 8 over 21 is less than 4/7, which is less than 3/5, which is less than 2/3. Hello and welcome to Pre-Algebra Practice Set number 35. In this video, we're going to look at some additional practice problems for our lesson on ratios and rates. So we want to start out with a simple exercise. And we're going to just write each ratio as a fraction and simplify. So our first ratio is the ratio 25 to 60. So remember, there's a few different ways we can write a ratio, and one of those ways is with a colon. So we're going to just write this using a fraction, and then we're going to simplify the fraction just like we normally would. So this leftmost number, this 25, is going to be the numerator for the fraction. The colon, we're going to put a fraction bar. And then the 60, the rightmost number, is going to be our denominator. Now, just like we always would, we would find the greatest common divisor, or the greatest common factor, between 25 and 60, and we would divide the numerator and denominator by that number. So for 25, it's going to factor to 5 times 5. And for 60, it's going to factor to, we could start with 5 times 12. And I don't really need to break it down any further, but I can just for a sense of completeness. 12 is 4 times 3, 4 is 2 times 2, so 2 times 2 times 3. But you can see that nothing in the prime factorization of 12 is going to cancel with the prime factorization of 25, right? You can't really do anything. All I can really do is cancel this 5 with this 5. That's why I was saying we can kind of stop when we get to 5 times 12. So what I'm left with is a 5 in the numerator and a 2 times 2 times 3, or a 12 in the denominator. And so our ratio is 5 to 12, right? And if you want to, you can go back. I know the instructions didn't say to, but you can go back and rewrite it using a colon, saying 5 to 12. What about the ratio 3 to 9? Again, my leftmost number is going to be in my numerator. Then my colon, I'm going to put a fraction bar. And then 9 is going to be my denominator. And if I look at 3 and 9, I know that the greatest common divisor is a 3, right? 3 divided by 3 is 1. 9 divided by 3 is 3, right? Or I can just think about it as, hey, I'm canceling a common factor of 3 between the numerator and denominator. So my simplified ratio, I'll have a 1 in the numerator, a 3 in the denominator, so we'd say it's 1 to 3, right? Or we could write it, again, using a colon, 1 to 3, like that. Okay, let's look at the ratio 42 to 14. Again, this 42 is going to go in the numerator. I'm going to put a fraction bar where my colon is, and then I'm going to have a 14 in the denominator. Now, the greatest common divisor between 42 and 14 is going to be 14. Because if I take 42 and divide by 14, I'm going to get 3, right? But again, if you want to kind of get a sense of completeness, you can factor 42 completely. It's 7 times 2 times 3. 14 is 7 times 2. And just cancel the common factors between numerator and denominator. Cancel this 7 with this 7, this 2 with this 2. Again, I've just removed a factor of 14 from the numerator and denominator. And I'm left with a 3 here. And remember, when something cancels completely, you put a 1 there. Now we end up with the ratio 3 to 1. If you get something like 3 over 1 or 2 over 1, or if you have 1 as your denominator, you leave it. Okay, I know when we just work with fractions, if we have 3 over 1, we just say, okay, that's equal to 3. When you're working with ratios, you're usually describing two quantities. So you want to leave the 1. If I have the ratio 3 boys to 1 girl, I want to leave that 1 there because it's describing something, right? I want to leave it there. So again, I could write this using a colon, just 3 to 1. All right, but what about the ratio 46 to 23? So again, writing this as a fraction, 46 will be in the numerator. The colon will put our fraction bar, and then 23 will be in the denominator. And we know that 46 divided by 23 is 2, so the greatest common divisor between these two would be 23. So if I think about dividing 46 by 23, I would get 2. Divide 23 by 23 and you get 1. So you get the ratio 2 to 1. And again, I have a 1 in my denominator. I know when we work with fractions, we would just write that as 2. When you're working with ratios, leave that in the denominator. Just say, okay, the ratio is 2 to 1. Or again, with a colon, 2 to 1, like that. All right, let's take a look at a word problem. So a playset contains 5 red marbles for every 3 green marbles. If the playset contains 32 marbles, how many are red and how many are green? So the first thing you want to do when you see this type of problem is write the ratio of red marbles to green marbles. So red marbles to green marbles. And again, we have 5 red for every 3 green, so this ratio is going to be 5 to 3. Now the next thing you're going to do is just add these two numbers together. So what is 5 plus 3? That's 8. And the reason you add these two together is you basically make one group. So one group contains 8 marbles. And in this group that contains 8 marbles, you're going to have 5 red marbles, and you're going to have 3 green marbles. Again, we know that from our ratio. If you have 5 red for every 3 green, when you have 8 marbles, that means you have 5 red and 3 green. The trick to figuring out this problem is just finding out how many of these groups you can make with the total number of marbles. So coming back up here, we see that we have 32 marbles in the play set. So basically all we would do is divide 32 by 8 to figure out how many of these groups we can make. All right, 32 is your total number of marbles. We divide that by 8, which is the number of marbles in one group, and we get 4. So that tells me the number of groups we can make, right? The number of these groups that we can make. So once we know that, all we need to do is multiply our numbers by 4, and we'll have our answers. So in other words, I just take the numbers from this one group and multiply them by 4 because I'd have 4 of those groups. So 5, the number of red marbles in one group, times 4, the number of groups, would give me 20. So in 4 groups, I would have 20 red marbles. So we're going to have 20 red marbles. Next, I would take 3, the number of green marbles I have in one group, multiply it by 4, the number of groups we're going to have, and we get 12. So we're going to have 12 green marbles. And we know that 20 over 12 is an equivalent fraction to 5 over 3 because all we really did was multiply this by 4 over 4. So our answer here is that out of 32 marbles, 20 marbles will be red and 12 marbles will be green. Now we want to look at finding some unit rates. So we're going to start out with what is the unit rate in miles per gallon. So the scenario is traveling 600 miles on 50 gallons of gas. So what we do to find the unit rate here, essentially we would set up a fraction where we have 600 miles in our numerator, and we're going to put 50 gallons in our denominator. So this is our rate. But again, we want to find the unit rate. So what we do is we take our number in the numerator, which in this case is 600, and we divide it by our number in the denominator, which in this case is 50. So if I had 600 divided by 50, I've already taught you at this point that you can cancel a 0 with the 0 here when you have a fraction, right? You're basically just removing a factor of 10 between the numerator and the denominator. That makes it simple because then you're looking at 60 divided by 5, and we know that's 12. So the numerator will be 12, and I'm going to put miles. The denominator, I know when we have 12 over 1, a lot of us will just write 12, but when you're working with ratios or rates, you always put your denominator even if it's 1, because we're talking about a comparison. So we would have 12 miles to 1, and instead of being plural, it's now singular, so to 1 gallon, 1 single gallon. So traveling 600 miles on 50 gallons of gas, the unit rate here in miles per gallon is 12 miles per 1 gallon of gas. This is one we should all be very familiar with. What is the unit rate in dollars per hour? So someone goes to their job and they're earning $75 in 5 hours. What do they make per hour? So we're going to set this up using a fraction. So we would have $75 in our numerator. In the denominator, we're going to have 5 hours. And all we need to do is basically divide the number in the numerator by the number in the denominator. So 75 divided by 5 is 15. So you'd have $15. And the denominator, since I divided by 5, the denominator is now 1. And instead of hours, I'm going to write hour. Right? I'm now going to have a singular form of that word. So now I find that if you're earning $75 in 5 hours, you're earning $15 per 1 hour, right? Or $15 for every 1 hour worked. All right, for the last problem, let's suppose that you visit a spa and you're given 2 different packages. So you want to find which is cheaper on a per visit basis. You have one option that says you can pay $144 for 12 sessions, and another option that says you can pay $195 for 15 sessions. So we want to find the unit rate for each so that we can compare the cost per visit. So in each case, I'm just going to set up a little fraction with the amount charged in the numerator. So in this case, it'd be $144. And the number of sessions in the denominator, so 12 sessions. Now all I need to do is divide the number in the numerator by the number in the denominator, and I'll have my unit rate. So 144 divided by 12 is 12. So this would be $12 per 1 session, right? 1 session. And I'll just write that here. This is $12 per session. All right, the next thing I'll look at is this one, $195 for 15 sessions. So $195 per 15 sessions. Now, if I divide 195 by 15, I get 13. So this would be $13 per 1 session. So let me write that here. So obviously, this one is going to be the better bargain. All right, $144 for 12 sessions is going to result in a cost of $12 per session. Again, that's cheaper than if you pay $195 for 15 sessions because you're paying $13 per session or $1 more per session. So we can just write that $144 for 12 sessions is the better bargain. Hello and welcome to Pre-Algebra Test Section 1 on ratios and rates. All right, so we just want to write each ratio as a fraction and simplify. So we start out with the ratio 8:4. So to write this as a fraction, we take the left part, which is 8, and we write it as the numerator. then your colon here, we're going to write that as a fraction bar, and then the 4, the right part, is going to be in the denominator. Once you have it as a fraction, you use your normal procedure to simplify a fraction. If you look at 8 and 4, really I know that this is division. 8 divided by 4 is 2, but you can kind of just think about it as canceling a common factor of 4 between the numerator and denominator, and you'd end up with 2 over 1. Now, in a lot of cases, if you have 2 over 1, you're working with fractions, you would simplify that and write it just as 2. When you're working with ratios, you want to leave your denominator of 1 if you have that. And the reason is because you're talking about the relationship between two things. So it might be that I have 2 boys for every 1 girl. It might be that I have 2 sodas for every 1 bag of chips. So on and so forth. So you want to put that 1 there and leave it there. Next, we're going to look at 16 to 24. So again, this left part here, 16 is going to go in the numerator. You'll have your fraction bar. Then the right part, 24, is going in the denominator. And the greatest common divisor between 16 and 24, if you think about 16, it's basically 2 to the 4th power. So the prime factorization contains only 2's. If you think about 24, it's 3 times 8. I know 8 is 2 to the 3rd power. But essentially, what you're going to do is think about the greatest common divisor as 8. Right? So 16 divided by 8 would be 2. 24 divided by 8 would be 3. So my simplified ratio would be 2 to 3. And again, all I did was I took 16 and I said, okay, it's 2 times 2 times 2 times 2. I took 24 and said 2 times 2 times 2 times 3. And I canceled the greatest common divisor, or again, the greatest common factor between the two numbers, right? That's going to be 8, right? 3 factors of 2. So I'm left with a 2 in the numerator and a 3 in the denominator. Again, that gives me a ratio of 2 to 3. What about 15 to 75? Well, I'm going to write this as 15 in the numerator over 75 in the denominator. And 75 is divisible by 15. So that means the greatest common divisor here is 15. So divide 15 by 15, you get 1. Divide 75 by 15 and you get 5. So this ratio is going to be 1 to 5. Next, we look at the ratio 100 to 10. So as a fraction, we'll put 100 in the numerator, 10 in the denominator. And we know that 100 is divisible by 10. 100 divided by 10 is 10. So this is going to simplify to 10 to 1. And again, when you have a 1 in the denominator and you're working with ratios, you have to leave it there because we're talking about a relationship. I might talk about the relationship of 10 red marbles to 1 blue marble. I might be talking about 10 students for every 1 teacher, so on and so forth. For the last one, I have the ratio of 12 to 3. So 12 is going to go on my numerator. 3 is going to go on my denominator. And we know that 12 is divisible by 3. 12 divided by 3 is 4. So essentially, this is just going to be 4 over 1. And again, if we're working with ratios and we have a 1 in the denominator, we just leave it there. So this is the ratio 4 to 1. Hello and welcome to Pre-Algebra Test Section 2 on ratios and rates. So a field trip contained 35 girls and 15 boys. We want to start out by asking, what is the ratio of boys to girls? So what is the ratio of boys to girls? Well, how many boys did I have? I had 15 boys. 15. And this is going to be over how many girls I had, which is 35. And when we work with a ratio, we always want to simplify. So to simplify, all we're going to do is divide the numerator and denominator by the greatest common divisor or the greatest common factor. 15 is 5 times 3. 35 is 5 times 7. So the greatest common divisor here is 5. 15 divided by 5 is 3. And 35 divided by 5 is 7. So the ratio of boys to girls would be 3 to 7. Meaning we had 3 boys for every 7 girls. Now the next question it asks is, what is the ratio of girls to boys? So if I already know what the ratio of boys to girls is, and remember we found that boys to girls was 3 to 7, all I have to do is flip that, right? Because I'm just flipping this. I'm just saying, okay, what is girls to boys? Well, I'll just flip this over and say, okay, well, it's 7 to 3, right? 7 girls for every 3 boys. And I can write that in a nice little sentence. So there were 7 girls for every 3 boys. Let's take a look at another one. So a football team had a win-loss ratio of 5-1. If they played a total of 12 games, how many were won and how many were lost? So again, the win-loss ratio is 5-1, meaning they won 5 games for every 1 that they lost. Now, if you kind of think about this as 5 plus 1 equals 6, 6 would be one group. 6 is one group, okay? And in one group, we have 5 wins and we have 1 loss. Now, how many equal groups of 6 can we make out of 12? Well, we can make 2, right? 12 divided by 6 is 2. So I know that I would have 2 of these groups. So all I need to do to figure out how many wins they had is multiply 5, the number of wins they had in one group, by 2, the total number of groups I can form with their 12 games. So 5 times 2 would give me 10. This is the number of wins in 12 games. And then for the number of losses in 12 games, I would take the number of losses they have in one group, multiply it by the number of groups. So 1 times 2 would give me 2. 1 times 2 equals 2. And this is the number of losses in 12 games. So if we want, we can make a nice little sentence. Again, how many were won and how many were lost? We could just say that the team won 10 games and lost 2 games. Hello and welcome to Pre-Algebra Test Section 3 on ratios and rates. Okay, so on a church trip, there are 4 boys for every 3 girls. If there are a total of 48 boys on the trip, how many girls are there? So this problem is actually a lot simpler than it seems. The first thing you want to do is just write the ratio of boys to girls. So boys to girls. We know this is going to be equal to 4-3. 4 boys to every 3 girls. If we're told that there's a total of 48 boys on the trip, just think about if I said, okay, this is going to be equal to 48 over something. Now we know when we work with fractions that we can get equivalent fractions by multiplying the numerator and denominator by the same number. What do I multiply 4 by to get to 48? Well, I multiply by 12. So if I multiply 12 by the denominator, I would get an equivalent fraction. 3 times 12 would give me 36. So now I know that I had 48 boys on the trip and 36 girls. So to answer my question here, I would just say there were 36 girls on the trip. Hello and welcome to Pre-Algebra Test Section 4 on ratios and rates. So we want to find each unit rate. And we're going to start out with a meal that contains 220 calories with 22 grams of fat. So we're going to find the unit rate for calories per gram of fat. So we're going to set up a little fraction here. And we're going to put 220 calories in the numerator. And we're going to put 22 grams of fat in the denominator. And essentially when you're finding a unit rate, you take the number in the numerator, you divide it by the number in the denominator. So 220 divided by 22 is pretty easy to do. If you recognize that 22 times 10, right, you take 22, put a trailing 0 at the end, so you'd have 220. So if you just reverse that, 220 divided by 22 is going to give you 10. Then you'd have calories. The denominator is going to be a 1. And then this is just going to be a singular form of this. So instead of grams of fat, you would put gram of fat. So now our unit rate is that we have 10 calories per every 1 gram of fat for this meal that we're eating. All right, next we're looking at traveling 320 miles on 20 gallons of gas. So again, set this up as a fraction. I'm going to put 320 miles in the numerator, and I'm going to put 20 gallons of gas in the denominator. And I'm trying to find the unit rate where I know how many miles per 1 gallon of gas. Or you might hear this often as your mileage per gallon, right? How many miles per gallon does your vehicle get? So divide 320 by 20. Well, there's a trailing 0 in each case, so I can just cancel that out. I'm just removing a factor of 10. And then essentially I'd have 32 divided by 2, that's 16. So this would be 16 miles per 1 gallon. 1 gallon of gas. Hello and welcome to Pre-Algebra Test Section 5 on ratios and rates. So we want to find each unit price, and I have here that's the price for 1 unit, and state the best deal. So we're going to look at each unit price again and find out what is the better cost per 1. So for example, when we look at 46 flash drives for $92, we're going to compare it to how much it is for 1 flash drive versus if we bought 12 flash drives for $36, right? In each case, I'm looking at the price per unit or the price for 1 flash drive. So essentially, I'm going to do $92 per 46 flash drives to get the price per unit there. What is 92 divided by 46? Well, that's going to give me 2. So this essentially means that I have $2 per 1 flash drive. So these are $2 each, you could say. Then the other one is we have $36 for 12 flash drives. We know that 36 divided by 12 is 3. So these are going to be $3 per 1 flash drive, or $3 each. Okay, $3 each. So what's the better deal? Well, obviously, if I buy 46 flash drives for $92, I'm paying $2 each. That's the better price per unit. It's the better deal. So we can just say that the better deal is 46 flash drives for $92. All right, the next one we're going to look at is 8 ink cartridges for $120 versus 23 ink cartridges for $368. So again, we're finding the price per unit or the price per ink cartridge. So $120 per 8 ink cartridges. So what's 120 divided by 8? Well, it's going to be 15. So this would be $15 per 1 ink cartridge. So these are $15 each. And then the other scenario would be that you pay $368 for 23 ink cartridges. So what is 368 divided by 23? We'll do that down here. 23 goes into 36 once. 1 times 23 is 23. Subtract here, you would get 13. Bring down the 8. 23 is going to go into 138 6 times. 6 times 23 is 138. Subtracting gets 0. So these are going to be $16 each, right? $16 per 1 ink cartridge. So $16 each. And we can see that 8 ink cartridges for $120 is the better deal, right? I only have to pay $15 each versus $16 each. So we would say that the better deal is 8 ink cartridges for $120. Hello and welcome to Pre-Algebra Practice Set number 36. In this video, we're going to look at some additional practice problems for our lesson on proportions. All right, so we want to use the equality test for fractions to determine if the fractions are equal. So remember, the equality test for fractions tell us that 2 fractions are equal if their cross products are equal. So we're going to start out with 3/15 is equal to 12 over 60. So to determine if this is true, we're going to find the cross products. So start with the denominator of this fraction times the numerator of this fraction. So what is 15 times 12? That's going to be 180. And then what is 60 times 3? Well, that's also going to be 180. So because the cross products are equal, the fractions are equal. So yes, these two fractions are equal. All right, for the next problem, we have 1/9, and we want to see if this is equal to 4/63. Again, we're going to find the cross products. So we're going to multiply 9 times 4, that's 36, and then 63 times 1, that's 63. So 63 and 36 are not equal, so no, these two fractions are not going to be equal. Here we have 57/57, and we want to see if this is equal to 319/319. For something simple like this, we don't need to form the cross products. We know that 57/57 is 1. We know that 319/319 is 1. So really we have the question, is 1 equal to 1? And the answer to that is yes. We know that 57 times 319 would be equal to 319 times 57. We don't need to go through and work that problem. So now we have 7/28, and we want to know if that's equal to 2/8. So again, form the cross products. So 28 times 2 is 56, and so is 8 times 7, that's also 56. So these two numbers are the same. So yes, these two fractions are going to be equal. So is 5/12 equal to 25/40? Again, find the cross products. So multiply 12 times 25, that would give us 300. Multiply 40 times 5, that would give us 200. 200 is not equal to 300, so this is a no. Okay, so we want to determine if we have a proportion here. And again, when we have a proportion, we have two ratios or two rates that are equal. So when we look at this first problem here, we see 3/7, and we want to know if that's equal to 9/21. Now, remember, when you work with ratios, you can write them as fractions. So really, I could just treat these as ratios. I could say, this is the ratio of 3/7. This is the ratio of 9/21. So we can see if these two ratios, or two fractions, are equal. And if they are, then we'd have a proportion. So again, we want to just find the cross products. So 7 times 9 would be 63. And 21 times 3. 21 times 3 is also 63. So yes, this is a proportion. So now in this problem, we have the ratio 500 words to 50 minutes. And then this ratio is 15 words to 3 minutes. So for this type of problem, you want to check the numerator and make sure that you have the same thing. So we have words here and words here. So that's the same. In the denominator, we have minutes and then minutes. That's the same. So once you've done that, you can just cross multiply the numbers. If the numbers are equal, then you have a proportion. So in other words, I would take 50 and multiply it by 15. 5 times 15 is 75. Put a 0 at the end, that's 750. And 3 times 500 would be 1,500. So these two are not equal, right? We do not have a proportion. Not a proportion. And if you want to think about this, these are basically rates. So if I wanted to transform each into a unit rate, I can see that they're not a proportion because 500 words being typed in 50 minutes, 500 divided by 50 would give me 10. So this is basically a unit rate of 10 words per 1 minute, or 10 words a minute. In this case, we have 15 words being typed in 3 minutes. So if I divide 15 by 3, I get 5. This is 5 words per 1 minute. These two are not equal. This person is typing at double the speed of this person. So not equal, so we don't have a proportion. All right, so here we have 13 juniors to 11 freshmen. And we're saying, is that equal to 39 juniors to 33 freshmen? So again, we have juniors and juniors, freshmen and freshmen, so that's okay. And we would just find the cross products for the numbers. So 11 times 39, that's 429. And then 33 times 13, that's also going to give us 429. So yeah, we do have a proportion here. So yes, we have a proportion. And if you just kind of simplify this right here, 39 is divisible by 3. So if I divide 39 by 3, I get 13. If I divide 33 by 3, I get 11. So you can see that those two are the same. What about 215 miles to 2 hours? We're saying, is that equal to 430 miles in 5 hours? Well, again, we have miles and miles. We have hours and hours. So we can cross multiply. 2 times 430 would be 860. And then 5 times 215 would be 1,075. These two numbers are not the same, so no, we don't have a proportion. Not a proportion. Okay, let's look at one final problem. So we have 3 defects for every 90 tires. We're saying is this equal to 6 defects for every 130 tires. So we have defects and defects. We have tires and tires. So we want to cross multiply here. 90 times 6. 9 times 6 is 54. Put a 0 at the end, that's 540. Then we cross multiply here. 130 times 3. 13 times 3 is 39. Put a 0 at the end, it's 390. So these two are not the same, right? 390 is not the same as 540. So we do not have a proportion. So not a proportion. Hello and welcome to Pre-Algebra Test Section 1 on proportions. So we want to determine whether each is a proportion. So we're going to start out with the ratio 8 to 10. We're saying is that equal to the ratio 2 to 5. Or again, you can kind of think about these as just fractions. 8/10 is that equal to 2/5. So again, if you want to figure this out, you'd use the equality test for fractions, right? You'd multiply the denominator of one fraction times the numerator of the other, right? You'd see if the cross products are equal, right? We're multiplying across. So 10 times 2 is 20. 5 times 8 is 40. These are not equal, so these are not going to represent a proportion. So no, not a proportion. What about 4 to 7? Is that equal to 8 to 14? Or saying 4/7 is that equal to 8/14? Again, find the cross products. So 7 times 8, that's 56. 14 times 4, that's also 56. So yeah, this is a proportion. All right, last one, we have the ratio of 2 to 3. Is that equal to the ratio of 5 to 7? Or again, is 2/3 equal to 5/7? Again, find the cross products. 3 times 5 is 15, and 7 times 2 is 14. The cross products are not equal, so therefore the fractions are not equal, or you could say the two ratios are not equal. Either way, you do not have a proportion. So not a proportion. Hello and welcome to Pre-Algebra Test Section 2 on proportions. Okay, so we want to determine whether each is a proportion. For the first problem, we have 4 yards of yarn to 3 sweaters. And we're saying is this equal to 20 yards of yarn to 15 sweaters. So again, if you match up the numerators and everything's the same in there, so you have yards of yarn, you match up your denominators, everything's the same, so we have sweaters and sweaters, then basically to determine if you have a proportion, you just cross multiply the numbers. So in other words, I take the denominator here, I take this 3, multiply it by the numerator here. 3 times 20 would be 60. Then I'm going to do the same thing over here. I'm going to take 15, and I'm going to multiply it by 4. That also gives me 60. So because the cross products are here, we're multiplying across, because the cross products here are equal, we have a proportion. So we just put yes here. We do have a proportion. All right, for this one, we have $6 to 3 pesos. We're saying is this equal to $8 to 7 pesos. So a lot of you can eyeball that and see that that's not going to be equal. Because something with a 6 and then a 3, we know that's basically the same as 2 to 1. For this to be 2 to 1, this would have to be 14 in the numerator, right? We can't have 8 over 7. That's not going to be 2 to 1. But we check it by cross multiplying anyway. We have dollars and dollars, pesos and pesos. So we would do 3 times 8, that's 24. And we do 7 times 6, that's 42. So no, we don't have a proportion because the cross products are not equal. So we're just going to put no. All right, here we have 13 men to 26 women. We want to know if this is equal to 39 men to 52 women. So we have men and then men. We have women and then women. So once you've checked that, we just form the cross products with the numbers. So we're going to take 26 and multiply it by 39. That's 1,014. Then we're going to take 52 and multiply it by 13. That's 676. So the cross products are not equal, so we don't have a proportion. So this is a no. Hello and welcome to Pre-Algebra Test Section 3 on proportions. Okay, we want to determine whether each is a proportion. So for the first problem, we have 5 grams of salt to 20 gallons of water. We want to know, is this equal to 30 gallons of salt to 100 gallons of water? So the first thing you do is kind of check what's in the numerator. We have grams of salt and grams of salt, so that matches up. Do the same for the denominator. We have gallons of water and gallons of water. So once we've done that, we're going to see if we have a proportion by cross-multiplying the number parts. So the cross products here, we'd have 20 times 30. 20 times 30. You could do 2 times 3, that's 6. Put 2 zeros at the end, so that's 600. And then we do 100 times 5, and that's 500. So your cross products are not equal. 500 is not equal to 600, so this is not a proportion. We would put no. For the next one, we have 8 defects for 120 rims. I want to know if this is equal to 48 defects for 720 rims. So again, we have defects, defects. We have rims, rims. So then we're just going to cross multiply the number parts. So 120 times 48 would be 5,760. And then 720 times 8 would be 5,760. So we do have a proportion here. When we form the cross products, we got 5,760 in each case. So this is a yes. Hello and welcome to Pre-Algebra Test Section 4 on proportions. All right, so we want to determine whether each is a proportion. So we're going to start out with 14 homes sold to 124 homes viewed. We want to know if this is equal to 7 homes sold to 62 homes viewed. So check what's in the numerator. We have homes sold and homes sold. That matches up. Do the same for the denominator. We have homes viewed and homes viewed. Then we would just find the cross products using the number parts only. So in other words, I would multiply 124 times 7. That's going to give me 868. Then I would multiply 62 times 14. That would also give me 868. So since the cross products here are equal, we know that we do have a proportion. So this is a yes. Okay, for the next one, we have 10 miles to 2 gallons of gas. I wonder if that's equal to 25 miles to 3 gallons of gas. Well, you can kind of eyeball and see that that's not going to work out. But again, you have miles and miles. That's what's in your numerator. You have gallons of gas and then gallons of gas. That's what's in your denominator. So that part checks out, right? We have the same thing in the numerator, same thing in the denominator. Then we just want to cross multiply. The number part in this denominator is 2. The number part in this numerator is 25. 2 times 25 is 50. Over here we have 3 times 10. That's going to give me 30. 30 does not equal 50, so we don't have a proportion. So we're just going to say no. Hello and welcome to Pre-Algebra Test Section 5 on proportions. So we want to determine whether each is a proportion. And we have 18 to 10. And we want to know if that's equal to 36 to 40. So we just cross multiply here. 10 times 36 is 360. 40 times 18, you could do 4 times 18. That's 72. Put a 0 at the end, it's 720. So 720 is not equal to 360. So no, this is not a proportion. What about 4 turtles to 7 dogs? Is this equal to 8 turtles to 14 dogs? So we have turtles and turtles in the numerator. We have dogs and dogs in the denominator. So again, we just find the cross products for the number parts. So we take 7 and multiply it by 8. That's 56. And then 14 would multiply that by 4. That's also 56. So yeah, we do have a proportion here. All right, for the last one, we have 3 women to 5 boys. We want to know if that's equal to 27 women to 40 boys. So we have women and then women. We have boys and then boys. So we just want to cross multiply the number parts. So 5 times 27 is 135. 40 times 3 is 120. So 120 is not the same as 135. So no, this is not a proportion. Hello and welcome to Pre-Algebra Practice Set number 37. In this video, we're going to look at some additional practice problems for our lesson on operations with mixed numbers. All right, so we just want to perform each indicated operation. And we're going to start out with some addition of mixed numbers. So when we add or subtract mixed numbers, typically what they're going to tell you to do is to add or subtract the fraction parts first, then follow that up by adding or subtracting your whole number parts. So for example, if we have 13 and 4/7 plus 16 and 2/7, Let me just write this in a different way so that you completely understand what's going on. This is written this way for convenience. Really, 13 and 4/7 is 13 plus 4/7. And same goes with 16 and 2/7, right? It's 16 plus 2/7. So to make this convenient for me, I'm going to reorder this. I'm going to write the fraction parts next to each other. I'm going to write the whole number parts next to each other. So I'm going to write 13 plus 16 plus 4/7 plus 2/7. Now, if I do the fraction parts first, basically I'm adding 4/7 and 2/7. We already have a common denominator. So to do that, basically I'm just going to add the numerators. 4 plus 2 is 6. Put that over the common denominator of 7. Once I have that result, let me just stick that over here. All I'm going to do after that is add 13 and 16. That result's going to be 29. So I'd stick that next to 6/7, and I'd get my answer of 29 and 6/7. And alternatively, if you wanted to, you could convert each number into an improper fraction and find the sum that way. But a lot of times that's going to be more of a hassle, right? This should be the easiest way in the majority of the cases you're going to see. Let's take a look at another one. We have 1 and 2/3 plus 6 and 5/18. So kind of the long way, again, I can rewrite this as 1 plus 2/3 plus 6 plus 5/18. I can reorder it to where the whole numbers are next to each other. So 1 plus 6 plus, I'll put the fractions next to each other, 2/3 plus 5/18. And I'm just going to add my fraction parts first. So to add 2/3 and 5/18, looking for the LCD there, I know it's going to be 18, right? 18 is 3 times 3 times 2, or 9 times 2. And we have a 3 here, so basically I'd multiply this top and bottom by 6 so that we'd have a common denominator of 18. So 6 times 2 would give me 12 over the common denominator of 18 plus 5 over 18. Now we just add the numerators. 12 plus 5 is 17, so this would be 17 over 18. So my fraction part is done. It'd be 17 over 18. Now I just add the whole numbers. 1 plus 6 would give me 7, and I have my answer. 7 and 17/18. All right, let's take a look at another one. We have 4 and 9/10 plus 11 and 3/5. So I'm going to add the fraction parts first, and I'm going to not write this whole thing out like I normally do. I'm just going to kind of eyeball these and bring them down. So 9/10 plus 3/5. Now, to get a common denominator here, the LCD is 10, right? Because 5 is not going to factor. 10 factors of 5 times 2, so the LCD is going to be 10. So I just need to multiply this by 2 over 2, and let's do that. So I'm going to have 9/10 plus 3 times 2 is 6 over 5 times 2, that's 10. So 9 plus 6 is 15, so I'd have 15 over 10. Now I can simplify this, but there's another problem. If I have an improper fraction here as my result, I have to rewrite it as a mixed number. And let me explain why. We're adding the fraction parts for these two mixed numbers here. So what we want is a proper fraction, because when we have a mixed number, we have a whole number part and we have a proper fraction. If I just throw 15 over 10 up here, or the simplified version, which would be 3/2, that's not going to be a proper fraction, and I'm not going to have a true mixed number. So let me go down here real quick. First, we'll simplify by just dividing the numerator and denominator by 5, the greatest common factor. 15 divided by 5 is 3. 10 divided by 5 is 2. So this will be 3/2. And to write this as a mixed number, remember, we just do 3 divided by 2. 2 goes into 3 once. 1 times 2 is 2. Subtracting, you get 1. So this would be 1 and 1/2. 1 and 1/2. So let me erase this. We're going to go back up to the top, and I'll show you what to do with it. So at this stage, we normally write our fraction part here, and we start adding the whole numbers. So I'm going to do the fraction part of that mixed number we came up with. It was 1 and 1/2, so I'm just going to put 1/2. Now, when I add my whole numbers, 4 plus 11, I'm going to throw a 1 in there, because that's what came off of that mixed number. So now I have 4 plus 11, that's 15, plus another 1, that's going to give me 16. So I have 16 and 1/2 as my answer. All right, let's look at some subtraction problems now. And we're basically going to do the same thing. We're going to subtract the fraction parts first, and then we're going to subtract the whole number parts last. So if I start off on this problem, I'm going to do 2/7 minus 1/7 to start. Now remember, with subtraction, it's not commutative, so the order is going to matter. The fraction part from the mixed number on the left is what's going to go on the left over here, and then we're subtracting away the fraction part from the mixed number on the right. So we have 2/7 minus 1/7. We already have a common denominator, so we just do 2 minus 1, that's 1, over the common denominator 7. So the fraction part for this will be 1/7. Now all we need to do is subtract the whole number parts. So we would do 9 minus 8. 9 minus 8 is 1. So our result here would be 1 and 1/7. All right, next we have 4 and 1/15 minus 2 and 3/5. So we're going to run into a little problem here. And when we get to it, I'm going to show you how to get around it. So we have 1/15, and we're going to subtract away 3/5. So the first thing I need to do is figure out what the LCD is going to be. Well, it looks like I can use 15, right? Because 15 is 5 times 3. 5 doesn't factor, so yeah, the LCD here is going to be 15. So I can multiply this by 3 over 3. So I'd have 1 over 15, or 1/15, minus 3 times 3, that's 9, over 5 times 3, that's 15. If I wanted to do 1 minus 9, I'm going to end up with a negative number. That's going to make this super complicated. So to make it easy for us, let's just erase this real quick and rethink this problem. So if I have 4 plus 1/15, again, that's what 4 and 1/15 is, I can rewrite this as 3 plus 1 plus 1/15, right? Mathematically, this is the same. Now, in fractional form, I can write 1 as any number, as long as it's not 0, divided by itself. So because this has a denominator of 15, I'm going to write this as 15 over 15. And what happens is I can write this as 3 plus 16 over 15. Now, typically, we're not going to write a mixed number like this, but for the purposes of performing this operation, we're temporarily going to do that. So let's just erase this real quick, and we're going to temporarily just rewrite this 4 and 1/15 as 3 and 16/15. And again, you're not going to typically see a mixed number written like this. We're just doing it for the purposes of performing the subtraction with the fractions. So then minus 2 and 3/5. And again, I'm going to do 16/15 now, minus 3/5. The LCD is still going to be 15, so I'd still multiply this by 3 over 3. And so what we'd end up with, we would have 16/15 minus 3 times 3 is 9, over 5 times 3, that's 15. 16 minus 9 is 7, so you'd end up with 7/15 here. So 7/15. So I'm going to put this as equal to, and I'm going to put 7/15 out here. And now we just need to subtract the whole number parts. So I have a 3 minus a 2. That's going to give me a 1. So 4 and 1/15 minus 2 and 3/5. Again, we temporarily wrote that as 3 and 16/15 minus 2 and 3/5. Either way, we end up with a result of 1 and 7/15. All right, now let's look at some problems with multiplication and division. Now, unlike with addition and subtraction, when we multiply or divide mixed numbers, we're going to convert them into improper fractions first. So 8/5, I can just leave that alone. That's already a fraction. I'm going to multiply this by, we have 3 and 3/14. 14 times 3 is 42. 42 plus 3 is 45. And then over 14. Now before we multiply, we always want to look to cross cancel. 45 divided by 5 is 9. So I can cancel this with this, and I'll get a 9. And I'll put a 1 here. If I look between 8 and 14, the greatest common divisor there will be 2. So divide this by 2, I get 7. Divide this by 2, I get 4. So what we're left with is 4 times 9, or 36 for our numerator, 1 times 7, or 7 for our denominator. So we get 36/7. Now, depending on who your teacher is or what textbook you're using, they might tell you that they want you to convert it back into a mixed number when you're done, or they might say, hey, 36/7, that's fine. So just to do one where we convert it back, you take 36 and you divide it by 7. 7 is going to go into 36 5 times. 5 times 7 is 35. Subtracting, you get 1. So remember, to write this as a mixed number, the quotient, which is 5, becomes the whole number part. The remainder becomes the numerator for your fraction part, and then your divisor is your denominator for the fraction part. So 36/7 is going to be equal to 5 1/7 as a mixed number. All right, let's take a look at 5 1/7 times 3 1/9. So I'm going to convert each into an improper fraction. 7 times 5 is 35, plus 1 is 36. So this is 36/7. And we're multiplying by 9 times 3 is 27, plus 1 is 28/9. Now when we look to cross cancel, 36 is divisible by 9. 36 divided by 9 is 4. So cancel this with this. I'll put a 1 here and a 4 here. 28 is divisible by 7. 28 divided by 7 is also 4. Cancel this with this. I'll put a 1 here and a 4 here. And we basically end up with 4 times 4, or 16, over 1 times 1, or 1. You can write 16 over 1, but basically it's just 16. All right, let's look at -2 times 12 4/5. So -2, I can write that as -2 over 1, just to make it convenient because we're working with fractions. And then times, we'll have 5 times 12, that's 60, plus 4, that's 64, over, and then we have 5 as our denominator. So nothing to cross cancel here. -2 times 64 is going to be -128, and then 1 times 5 is 5, so we just end up with -128 over 5. All right, let's look at some with division. We have 13 1/2 divided by 5 5/6. So 13 1/2, we have 2 times 13, that's 26, plus 1 is 27, over 2. And divided by, for 5 5/6, 6 times 5 is 30. 30 plus 5 is 35, over 6. And again, when you're dividing fractions, you're going to take this left fraction and leave it unchanged. So 27 over 2, or 27 halves, you don't really touch that. Then you're going to multiply by the reciprocal of 35 over 6, which is going to be 6 over 35. Now, looking between these fractions, what can we cross cancel here? I know 6 is divisible by 2. 6 divided by 2 is 3. So cancel this with this. Put a 1 here and a 3 here. Between 27 and 35, there's nothing I can really do. 27 is 3 factors of 3, right? 3 times 3 is 9. 9 times 3 is 27. And 35 is 5 times 7. So nothing else I can cancel. So I basically do 27 times 3. That's going to give me 81. And this is over 1 times 35, or 35. So we get 81 over 35 as our answer. All right, for the last problem, we have 2 3/4 divided by 1 7/10. So again, I'm going to convert each of these into an improper fraction and then do my division. So 4 times 2 is 8. 8 plus 3 is 11. So you'd have 11 over 4. And we're dividing by 10 times 1, that's 10. Plus 7 is 17 over 10. So to divide the fractions, again, 11/4 stays unchanged. And we multiply by the reciprocal of 17/10, which is 10/17. So looking here to cross cancel, I know that the greatest common divisor, or the greatest common factor between 10 and 4, would be 2. So if I divide this by 2, I get 5. If I divide this by 2, I get 2. So then I do 11 times 5, that's 55. Over 2 times 17, that's 34. So we end up with 55 over 34 as our answer. Hello and welcome to Pre-Algebra Test Section 1 on operations with mixed numbers. All right, so we want to perform each indicated operation. We're going to start out with 6 1/5 plus 3 2/5. So like I told you in the lesson, if you're adding or you're subtracting mixed numbers, kind of the easiest way to do it is going to be to add or subtract your fraction parts first, and then follow that up by adding or subtracting your whole number parts. So just to let you see what we're actually doing, let's rewrite this. So instead of 6 1/5, I'm going to write 6 plus 1/5. Remember, 6 1/5 written this way is for convenience, right? We don't put this plus in here, but we should know that it's actually there, right? 6 1/5 is really 6 plus 1/5. Then we have plus. Next we have 3 2/5. So I'm going to write 3 plus 2/5. And then because addition is commutative, I can reorder it. So let's put our whole numbers next to each other. So 6 plus 3. Let's put our fraction parts next to each other. So 1/5 plus 2/5. And now let's add the fraction parts first. So if I have a common denominator of 5 already, really I just need to add the numerators. So 1 plus 2 is 3. So really this would just be 3/5. And 6 plus 3, the whole number parts, add that next. 6 plus 3 is 9. So we get 9 plus 3/5. And if we write this as a typical mixed number, we don't put the plus sign in, right? For convenience, we just write 9 and 3/5, right? Like this. All right, let's take a look at another one. We have 3 and 1/3 plus 2 and 2/7 plus 1 and 1/4. Now, for convenience, I'm just going to write 1/3 plus 2/7 plus 1/4 down here. So I'm just going to take care of the fraction part first. And then once I have my answer, I'm just going to go back and add the whole numbers. So if I have 1/3 plus 2/7 plus 1/4, the LCD, the least common denominator, is going to be 3 times 7 times 4. And that's because 3 is prime, 7 is prime, and 4 is 2 times 2. So really the best I can do for the LCD is the product of the denominators. So 3 times 7 is 21, and 21 times 4 is 84. So I'm going to have to multiply 1/3 by 28 over 28. I'm going to multiply 2/7 by 12 over 12. And I'm not going to fit this on my screen, so I'm just going to write this down here. I'm going to have to multiply 1/4 by 21 over 21. So 1 times 28 is 28. And we know that 3 times 28 is going to give us 84. Then plus, next we have 2 times 12, that's 24. Over 7 times 12, again, we know that's 84. Then plus, we have 1 times 21, that's 21. Over 4 times 21, that's, again, 84. So now that we have this set up with a common denominator, we just need to add the numerators. So let me erase this real quick. And I'm going to do that vertically. So we have 28, 24, and 21. So if we sum this here, 8 plus 4 is 12, 12 plus 1 is 13. Carry the 1, 1 plus 2 is 3, plus 2 is 5, plus 2 is 7. So this would give me 73 over 84 as my fraction part. So let's erase everything, and we come back up here, and again, the fraction part is 73 over 84. So now the hard work is behind us, and I just need to add the whole numbers. So I have 3, 2, and 1. So 3 plus 2 is 5, 5 plus 1 is 6. So we get 6 and 73 over 84 as our answer. Hello and welcome to Pre-Algebra Test Section 2 on operations with mixed numbers. So for our problems today, we just want to perform each indicated operation. And what we're going to be doing, we're going to be adding and subtracting some mixed numbers. So hopefully you've already seen the lesson, but just in case you haven't, when we perform addition or subtraction with mixed numbers, the preferred method is to add or subtract the fraction parts first. So with this problem, here's your fraction parts, and we're doing addition, so we would add the fraction parts first, and then we would follow that up by adding the whole number parts. So here's your whole number parts. Now I'm going to start this problem out 5 and 3/7 plus 7 and 9/11 by just rewriting it. Now most of you will know at this point that 5 and 3/7 mathematically is really 5 plus 3/7. We just write it like this for convenience, right? But really it's 5 plus 3/7. Now I'm going to write plus. I'm going to do the same thing to 7 and 9/11. So 7 plus 9/11. Okay. Now because addition is commutative, I'm allowed to reorder it. So what that means is I can write the whole numbers next to each other. So 5 plus 7. And then I can write the fractions next to each other. So 3/7 plus 9/11. So the first thing I'm going to do is I'm going to add the fraction parts together. And some of you have emailed me and asked, why do we do the fraction parts first? Well, this is the perfect example to show you why. So if we add 3/7 and 9/11, you're going to see that we're going to have an additional step when we get the answer. So the first thing I want to do is get my LCD. So my LCD here, if I look, I have a 7 for a denominator and I have an 11. Those are each prime numbers, so my LCD is going to be the product of the denominators, which is 7 times 11 or 77. So I'm going to multiply this fraction by the other fraction's denominator, top and bottom. So 11 over 11. And I'm going to do the same thing over here. 9 over 11, I'm going to multiply that by 7 over 7. So in each case, I'm now going to have a denominator of 77. So 11 times 3 is 33. Let me just scroll down a little bit, get a little room going. So 33, and that's of course over 77. And then plus 9 times 7, that's 63. And again, of course, that's over 77. Now, when we add the numerators here, we have 33 plus 63. The best way to do that mentally is to just say, okay, just kind of cut this 3 off and cut this 3 off. If you think about having 30 plus 60, that's 90. So I know that part's going to be a 9. And then just do 3 plus 3. 3 plus 3 is 6. So this would be 96. Okay, and this, of course, is going to be over the common denominator of 77. So this is why we add the fractions together first, because stuff like this happens. So what happens is I have an improper fraction. So let's say I go back up 96 over 77, and I continue with my problem. I say, okay, 5 plus 7 is 12, so I get 12, and 96 over 77. Well, that's not technically a mixed number because a mixed number is a whole number part, and then a proper fraction part. This is not a proper fraction. This is an improper fraction. So when you find that you get this result where you have an improper fraction, you have to go through and do one additional step. What we're going to do, let's scroll back down. Where we find we get an improper fraction here, we're going to convert it to a mixed number. So 96 divided by 77. 77 will go into 96 only once. 1 times 77 is 77. If we subtract here, we would borrow. This will become 8, and this will become 16. 16 minus 7 is 9. 8 minus 7 is 1. So what this is going to be is 1 and 19 over 77. Okay, so let me erase this. We're going to go back up to the top. So I'm just going to write this here as 5 plus 7 plus, remember I had 1 and 19 over 77. So I'm going to write that as 1 plus 19 over 77. And once I write it like that, it's pretty obvious what we're going to do now. We're just going to add the whole numbers together. 5 plus 7 is 12. 12 plus 1 is 13. And then we would have plus 19 over 77. Well, we can just write this as a mixed number as 13 and 19 over 77. All right, for the next one, we have 8 and 5/7 minus 3 and 2/3. Now, with subtraction, it's basically the same thing. We want to subtract the fractions first, and then once we're done with that operation, we want to subtract the whole numbers. Now, in this particular case, we have 5/7, and we're going to subtract away 2/3. It has to go in that order because, remember, subtraction is not commutative like addition. So if I think about 5/7 minus 2/3, the first thing I want to think about is 5/7 bigger than 2/3? Because if it's not, it's going to produce a negative result. And for that situation, we have to use a little trick. So 7 times 2 is 14. 3 times 5 is 15. So 5/7 is the bigger fraction, so we don't have to worry about that in this case. So let's go through and just do our subtraction. First, we need to find the LCD. So the LCD for these fractions, 7 is a prime number, so is 3. So the best we can do is 7 times 3, or 21. So I'll multiply this fraction by 3 over 3. I'll multiply this fraction by 7 over 7. So 3 times 5 is 15, over 3 times 7, that's 21. Subtract away, 2 times 7 is 14, over 3 times 7, that's also 21. 15 minus 14 is 1, over the common denominator of 21. So the fraction part for this mixed number is going to be 1 over 21. Now we're done with that part, and we just need to talk about subtracting 8 minus 3. Right? 8 minus 3 is simply 5. And just like that, we have our answer. It's 5 and 1 over 21. Hello, and welcome to Pre-Algebra Test Section 3 on operations with mixed numbers. So we just want to perform each indicated operation. And we're going to look at 13 and 4/9 minus 9 and 6/7. So as I told you in the lesson, when you're adding or you're subtracting mixed numbers, you want to add or subtract the fraction parts first, and then follow that up by adding or subtracting the whole number parts. So with this problem, I'm going to just subtract 4/9 minus 6/7 first. That will give me the fraction part for the mixed number that I'm forming. So 4/9 minus 6/7. So 9 is 3 times 3. 7 does not factor. So my LCD here would be 9 times 7, or 63. So I can multiply this by 9 over 9, and this by 7 over 7. And we would have 7 times 4, that's 28. Over 9 times 7, or 7 times 9, that's 63. minus 6 times 9, that's 54, over 7 times 9, that's 63. So we have a bit of a problem here. And we see that 28 is actually less than 54. So if we do this subtraction, we're going to end up with a negative result. So we don't typically perform the operation this way. What we would do, let's just erase this real quick. We would kind of rewrite our mixed number temporarily. So instead of 13 and 4/9, I want you to think about this as 12 plus 1 plus 4/9. Remember, 13 and 4/9 is really 13 plus 4/9. So if I write it this way, these two are equal, right? They are the exact same thing. I just wrote it differently. Now, in order to kind of match this up, instead of writing this as 1, I'm going to write it as 9/9. Okay, 9/9. Remember, 9/9 is really 1. So what that allows me to do is add this and this together. 9/9 plus 4/9 would give me 13/9. So what I've done is I've temporarily rewritten this mixed number as 12 plus 13/9. And now, when I perform the operation with the fractions, I will have a result that is not negative. So I'll write this as 12 and 13/9 minus 9 and 6/7. And I know this is not technically correct because this is not how you write a mixed number, right? A mixed number is always a whole number part and then a proper fraction. But again, we're just temporarily doing it this way so that we can do our operation and not have it all messy. So we would do 13/9. We would do 13/9 minus 6/7 now. And it's the same LCD. So I'm going to multiply this by 7 over 7. I'm going to multiply this by 9 over 9. And let's scroll down and see what this gives us. So 7 times 13 is 91. And we know that 7 times 9 is 63. And then we're subtracting away 6 times 9, that's 54. Over 7 times 9, again, that's 63. And so 91 minus 54 is 37. So we'd have 37 over 63. And let's erase everything and just go back up to the top. So for my fraction part, I'm going to put 37 over 63. Now I just need my whole number part. So I'm only going to be subtracting with 12 here. Remember, I changed the way this mixed number was so that I could perform the operations with the fractions. So instead of having 13, I now only have 12. Make sure you remember that. So I'd have 12 minus 9, and that's going to give me 3. So the whole number part for this mixed number is going to be 3. And then we already have the fraction part. So our answer is 3 and 37 over 63. All right, let's take a look at another one. We have 15 and 2/13 minus 6 and 4/5. So again, we want to subtract the fraction parts first. So I would think about 2/13 minus 4/5. And you can kind of eyeball those two fractions at this point and see that you would get a negative result, right? 2/13 is smaller than 4/5. And if you kind of suspect that's the case and you don't want to go through and actually do the subtraction, again, we know how to compare fractions. 13 times 4 is 52, and 5 times 2 is 10. So this is the bigger fraction, so if I subtract it away, I will in fact get a negative. So let me erase all this real quick, and we're going to use our little trick again. So instead of having 15, I'm going to rewrite this as 14, then plus, where I took 1 away, I'm now going to add 1 to this fraction. So I'm going to temporarily rewrite 1 as 13 over 13. And that's just so I can have a common denominator with 2/13. And so 13 plus 2 would give me 15. So really what I'm doing is I'm going to temporarily write this as 14 and 15/13. So let's erase this. And then we still have minus 6 and 4/5. So now when we work with our fractions, we're going to have 15/13. And we're going to subtract away 4/5. Now, the LCD here, 13 is prime, so is 5. So the best we can do is just multiply 13 times 5 and get 65 for our LCD. So I'm going to multiply this fraction by 5 over 5. I'm going to multiply this fraction by 13 over 13. And so what we're going to get, 15 times 5 is 75. Again, 13 times 5 is 65. And we're subtracting away. 4 times 13, we did that earlier. We know that's 52. And then 5 times 13 again is 65. So now we just need to subtract 75 minus 52. That's going to give us 23. So we would have 23 over 65 for the fraction part of this mixed number that we're building. So 23 over 65. So equals, I'm going to put 23 over 65 here. And what's my whole number part? Well, remember, if you didn't write it this way, you have to remember that you have 14 now, right? You don't have 15 anymore because you lent one to your fraction part so you could do that operation. So having one less, we start with 14, we subtract away 6, we would get 8. So I put that here as my whole number part for that mixed number, and we get our answer, which is 8 and 23 over 65. Hello and welcome to Pre-Algebra Test Section 4 on operations with mixed numbers. All right, so we want to perform each indicated operation, and we have 4 2/3 times 6 3/5. Now in the previous test sections, we worked with adding and subtracting mixed numbers. Now when we start multiplying and dividing mixed numbers, the way we do it changes a little bit. So instead of working with kind of the mixed numbers in this form, we're going to convert them into improper fractions first, then do our multiplication. Now if your teacher asks you for it, go ahead and convert them back into a mixed number. So to convert this one 4 2/3, I'd multiply 3 times 4 and get 12, then add 2 and I'd have 14 thirds. And I'm multiplying by, for 6 3/5, I'd multiply 5 times 6, that's 30. Then add 3, I'd have 33 over 5. So we're multiplying these two together, and we can see that we can cross cancel here. 33 and 3 basically share a factor of 3. So I can divide this by 3 and get 11, divide this by 3 and get 1. Nothing else I can really do to cross cancel, so I would just multiply 14 times 11, and I'd get 154. And this is over 1 times 5, or 5. So we'll end up with 154 fifths. And again, if it's required, you can change this back into a mixed number. Again, just divide. You take 154 and divide it by 5. 5 goes into 15 3 times. 3 times 5 is 15. Subtract, you'd get 0. Bring down the 4. 5 is not going to go into 4, so I'm going to put a 0 here. 0 times 5 is 0. Subtracting, you'd have 4. So essentially, this is 30 with a remainder of 4. So to write our mixed number, the 30, your quotient, is the whole number part. 4, your remainder, is the numerator for the fraction part. And then 5, your divisor, is the denominator for the fraction part. So this 154 fifths is really the same thing as 30 and 4 fifths when you write it as a mixed number. Okay, next we have 2 and 4 fifths times 1 and 5 sixths. Again, I'm going to convert each into an improper fraction to start. 5 times 2 is 10, plus 4 is 14. So you'd have 14 fifths times 6 times 1 is 6, plus 5 is 11 over 6. And so now we're going to look to cross cancel. Nothing between 11 and 5, but between 14 and 6, I have a common factor of 2. So divide this by 2, I get 7. Divide this by 2, I get 3. So then 7 times 11 is 77. Over 5 times 3, that's 15. So you get 77 fifteenths as your answer. And again, your teacher might require you to write this as a mixed number. If they do the division and set yourself up a mixed number. All right, we got one final problem here. We have -3 times 4 and 1/15. So for convenience, because we're working with kind of mixed numbers and fractions, I'm going to write -3 as just -3 over 1. And then we're going to convert 4 and 1/15 into an improper fraction. 15 times 4 is 60, plus 1 is 61, and then over 15. Now between -3 and 15, I have a common factor of 3. If I divide this by 3, I'd end up with -1. If I divide this by 3, I'd end up with 5. So really I have -1 times 61, which is -61, over 1 times 5, or 5. So we get -61 fifths as our answer. Hello and welcome to Pre-Algebra Test Section 5 on operations with mixed numbers. All right, so we want to perform each indicated operation. We're going to start out with 12 1/2 divided by 5 2/3. So again, if you're working with multiplication and division for mixed numbers, the easiest way to do it is to convert each into an improper fraction, perform your operation, and then if you need to, take your result, change it back into a mixed number. So I'm going to take 12 1/2, and I'm going to rewrite it as 2 times 12 is 24, plus 1 is 25, so 25 halves. And then I'm dividing by, I have 5 2/3. I'm going to rewrite this as 3 times 5, that's 15, plus 2 is 17, so 17 thirds. All right, so to divide two fractions, I take the first fraction, or the leftmost fraction, 25 halves, leave it unchanged, multiply by the reciprocal of the second fraction, So 17/3, if I flip that, I'm going to have 3/17. And I look to see what I can cross cancel, and there's nothing I can really do here. So I just multiply. 25 times 3 is 75, and 2 times 17 is 34. So we'll end up with 75 over 34 as our answer. All right, next we're going to look at 7 1/2 times 8 4/5. So again, what I want to do is change each into an improper fraction. So 2 times 7 is 14, plus 1 is 15. So I'd have 15 halves. And I'm multiplying by 5 times 8 is 40. 40 plus 4 is 44. So 44/5. So I can do some cross canceling here. 15 divided by 5 is 3. So I can cancel this with this. I'll put a 1 here and a 3 here. I can cancel a common factor of 2 between 44 and 2. So cancel this with this. This will be 1, and this will be 22. So now I'll just multiply 3 times 22, that's 66. And that'll be over 1 times 1, or 1. So really I don't have to write that as 66 over 1. I can just write 66. All right, for the next one I have -3 divided by 2 1/5. So -3. And for convenience, I'm going to write that as -3 over 1. Then divided by 2 1/5. I'm going to convert that to an improper fraction. 5 times 2 is 10, plus 1 is 11. So we'd have 11/5 there. So now to divide, I'd have -3 over 1 times the reciprocal of this fraction, which would be 5/11. Nothing to cross cancel. So I do -3 times 5, that's -15. Over 1 times 11, that's 11. So I get -15/11 as my answer. All right, let's look at one final problem. We have -6 times 11 1/3. So I'm going to write this as -6 over 1, and then times, change this to an improper fraction. 3 times 11 is 33, plus 1 is 34, so 34/3. So before I multiply, I want to look to see if I can cross cancel. I have a -6 and I have a 3. Forget about the negative for a minute. If I just think about the relationship between 6 and 3, 6 divided by 3 is 2. So I can cancel this 6 with this 3. I'll get a 2 here. I'll put a 1 there. So now this is a -2. And -2 times 34 is going to give me -68. And this is over 1 times 1, or 1. And I can put -68 over 1, but really that's just -68. So that's going to be my answer. Hello and welcome to Pre-Algebra Practice Set number 38. In this video, we're going to look at some additional practice problems for our lesson on complex fractions. All right, so to start, we just want to simplify each complex fraction. And in the lesson, I taught you kind of 2 ways to do it. The first way you would do it is just to simplify the numerator and denominator separately, and then kind of to perform the main division. The other way to do it is to multiply the numerator and the denominator of the complex fraction by the LCD, the least common denominator of all fractions involved. Now, I'm going to start out by just simplifying the numerator and denominator separately, and then kind of in the last few problems, we'll do it the other way. So we're going to start out with 1/8 plus 4 over 7 plus 5/3. So I'm going to start out by just simplifying the numerator. So we'd have 1/8 plus, I could write 4 as 4 over 1, but really I've got to get a common denominator here to add. So the LCD I'm going to be able to have is an 8, right? Because I could write this as 4 over 1. Between 8 and 1, the least common denominator is going to be an 8. So I can just multiply 4 by 8, that's going to give me 32. And multiply 1 by 8, that's going to give me 8. And we know that 32 over 8 is the same thing as 4. Now I can add. 1 plus 32 is 33. So this is going to end up being 33 over 8. So I'm just going to erase this and put that this is 33 over 8. Next we have 7 plus 5/3. Again, I'm going to write this over 1. And I can see that my LCD between 1 and 3 is going to be 3. So just multiply this by 3 over 3. 7 times 3 is 21. Over 1 times 3, that's 3. And then we're adding to that 5 over 3. 21 plus 5 is 26. So we're going to end up with 26/3 here. And so now we just perform a division, right? We have 33 over 8 divided by 26 over 3. So 33 over 8 times the reciprocal of 26 over 3 would be times 3 over 26. And there's nothing really we can cross cancel here. 33 is 3 times 11. 3 is prime. 8 is 3 factors of 2. And 26 is 13 times 2. So I'm just going to multiply. 33 times 3 is 99. And 8 times 26 is 208. So when we simplify our complex fraction, we end up with 99 over 208. All right, now we're going to look at 3/4 plus 1/7 over 5/6 plus 7/8. So again, we're going to simplify the numerator and denominator separately, then do the main division. So if I think about 3/4 plus 1/7, the LCD here, if you look at 4 and you look at 7, 4 is 2 times 2, 7 is prime. So really the LCD is going to be 4 times 7 or 28. So I'm going to multiply this fraction by 7 over 7 and this fraction by 4 over 4. So what I'm going to get is 3 times 7 or 21 over 28 plus 1 times 4 or 4 over 28. So 21 plus 4 is going to give me 25, and this is over the common denominator of 28. So 25 over 28 is going to be my simplified numerator. Now what about my denominator? I have 5 over 6 plus 7 over 8. So if I think about the LCD here, the LCD, for the LCM between 6 and 8, 6 is 2 times 3, and 8 is 3 factors of 2. So really it would be 3 factors of 2 and 1 factor of 3. So it would be 8 times 3 or 24. So I would need to multiply this by 4 over 4, and I would need to multiply this by 3 over 3. So 5 times 4 is 20, over 6 times 4 that's 24, plus 7 times 3 that's 21, over 8 times 3 again that's 24. Add the numerators, 20 plus 21 is 41, over the common denominator of 24. So my simplified denominator is going to be 41 over 24. So now we just perform the division. We have 25 over 28 divided by 41 over 24. So this fraction here stays the same, 25 over 28. And we're going to multiply by the reciprocal of this fraction, which is 24 over 41. And it looks like I can cross cancel here. 28 is divisible by 4, and so is 24. So if I divide 28 by 4, I'd get 7. If I divide 24 by 4, I'd get 6. So now I'd end up with a problem 25 times 6, which is 150, over 7 times 41, which is 287. So my result is 150 over 287. Okay, now we want to simplify each complex fraction using the LCD method. So we're going to look at 1/8 plus 5/12 over 3/5 plus 2/15. Now, I don't know if this method is faster or slower for you, but you need to know both because your teacher might ask you to do the problem a specific way on a test. So to use the LCD method, find the LCD for all the fractions involved. So the LCD is going to be the LCM of 8, 12, 5, and 15. So if we look at these numbers here, 8 is 3 factors of 2. So 2 times 2 times 2. 12 is 2 factors of 2, which we've already covered, and 1 factor of 3. So throw in a factor of 3. 5 is prime, it doesn't factor, throw that in. And then 15 is 5 times 3. We already have that in there. And so we multiply. 3 factors of 2 is 8, times 3 is 24, times 5 is going to give us 120. So the LCD here is 120. So now what we're going to do is multiply the numerator of the complex fraction by 120. And you can put times 120 over 1 if that makes you feel more comfortable. And we're also going to multiply the denominator of the complex fraction by 120. And again, I'm going to put 120 over 1 as well. So to do this, we use the distributive property. So 120 over 1 times 1/8. 120 over 1 times 1/8. And I'm going to do that down here. So 120 divided by 8 is 15. So essentially, we cancel this with this and we get 15. So you'd have 15 times 1 over 1 times 1, or just 15. Right? You could write 15 over 1 if you want, but you really don't need to. So we just write this as 15. So then plus. Next, I do 120 over 1 times 5/12. So 120 over 1 times 5/12. You can cancel this with this and get 10. All right, 120 divided by 12 is 10. So then you'd have 10 times 5, that's 50. And this is over 1 times 1. 50 over 1 is the same thing as 50. So we'll just write 50. Now we're going to work on the denominator. So again, I'm doing the same thing. I'm going to have 120 over 1 times 3/5. So 120 over 1 times 3/5. So 120 over 5 is going to be 24. All right, this will cancel with this and give me 24. then 24 times 3 is 72. So this would be 72 over 1, or just 72. Then plus. Next, we're going to have 120 over 1 times 2/15. 120 divided by 15 would give me 8. So this would cancel with this and give me 8. 8 times 2 is 16. And of course, it's over 1 times 1, or just 1. So 16 over 1 is the same thing as 16. I'll scroll back up here. 15 plus 50 is 65. 72 plus 16 is 88. So there will not be any factors in common between 65 and 88. So that's going to be your final answer. 65 over 88. So let's look at one final problem. We have 3/7 plus 2/13 plus 1/14. And this is over 3/13 minus 4/7. So what's our LCD? Again, that's going to be the LCM of all the denominators involved. So 7, 13, 14, and then we have 13 and 7. That's just a repeat here. So we would have 7 times, 13 is also prime, times, 14 is 7 times 2, so just times 2. So 7 times 13 is 91, then times 2 is 182. So what I'm going to do is multiply the numerator and denominator of the complex fraction by 182. So I'm going to be multiplying the numerator and the denominator, again, by 182. And again, to do this, we use the distributive property. So what's 182 times 3/7? 182 times 3/7. Well, 182 divided by 7 is 26. So this would cancel with this and give you 26. And then 26 times 3 would give you 78. So this would be 78. Then plus, next I do 182 times 2/13. So 182 times 2/13. So 182 divided by 13 is going to give me 14. So we'd have 14 times 2, that's 28. Then plus, next we're going to have 182 times 1/14. And 182 divided by 14 is 13. So you just have 13 times 1, or 13. And then this is over. We're going to do the same thing down here. We're going to multiply 182 times 3 over 13. Again, 182 divided by 13 is going to give me 14. So then 14 times 3 is 42. So this is going to be 42 minus. Then the last thing we're going to do is multiply 182 times 4/7. So 182 times 4/7. 182 divided by 7 is going to give me 26. And then 26 times 4 is 104. So this is going to be minus 104. All right, so now let's continue this down here. We have 78, 28, and 13. So we're adding these numbers in the numerator. Let's just do that with a vertical addition real quick. 8 plus 8 is 16. 16 plus 3 is 19. Put a 9 down, carry the 1. 1 plus 7 is 8. 8 plus 2 is 10. 10 plus 1 is 11. So the numerator is going to be 119. Numerator is going to be 119. Let me just write that right here. Okay, so that part's taken care of. Next, we have 42 minus 104. So we can really think about this as 42 plus a negative 104. We know the sign is going to be negative. And then we're just going to do 104 minus 42. So 104 minus 42. 4 minus 2 is 2. Borrow here. That becomes 0. This becomes 10. 10 minus 4 is 6. So you get 62 there. And of course, this is negative. So you get 119 over negative 62. Or again, when you have a fraction and the numerator is positive and the denominator is negative, really the whole thing was just negative. So you can just stick the negative out in front and say you have negative 119 over 62 like that. Nothing we can simplify between the numerator and denominator. So this is going to be our final answer. Hello and welcome to Pre-Algebra Test Section 1 on complex fractions. So we want to simplify each complex fraction. And we just have one problem to work on. So we're going to start out with 2/9 minus 1/27. And this is over 4/5 minus 3/10. So there's two ways I taught you to do this in the lesson. The first method is to simplify the numerator and denominator separately, then perform the main division. Kind of the second way is to multiply the numerator and denominator of the complex fraction by the least common denominator of all the denominators involved. So we're going to use the first method for this problem here. And then when we get to our fourth and fifth section of the test, we'll use the other method. So I'm going to simplify again in the numerator and denominator separately. So for the numerator of the complex fraction, I have 2/9 minus 1/27. So I need a common denominator, and the LCD would be 27, right? I have 9 and I have 27. And 27 you can just think of as 3 times 3, which is 9, times 3 again. So the LCD would be 27. So I can just multiply this by 3 over 3. 2 times 3 would be 6. 9 times 3 would be 27. So I'd have 6 over 27 minus 1 over 27. And then we would do 6 minus 1, that's 5, over the common denominator of 27. Now in the denominator, we have 4/5 minus 3/10. So the LCD here would be 10, right? 10 is 5 times 2. This denominator is just 5. So I can multiply this by 2 over 2. 4 times 2 would give me 8. And then over 5 times 2, which is 10. And then we're subtracting away 3/10 here. So I'd do 8 minus 3, that's 5, over the common denominator of 10. So let me erase this just so we have some room. And I'm just going to write that we have 5 over 27. And this is divided by, or you could say over, 5/10. So basically now we just have a division problem. We have 5/27 divided by 5/10. So 5/27 would stay the same. And we'd multiply by the reciprocal of 5/10, which would be 10 over 5. You can see you can cancel this 5 with this 5. And essentially you're just left with 10 over 27. 27 is 3 factors of 3. And 10 is 5 times 2. Nothing you can really do to cancel there. So your answer again would just be 10 over 27. Hello and welcome to Pre-Algebra Test Section 2 on complex fractions. So we want to simplify each complex fraction. And again, I taught you in the lesson 2 different methods to do this. We're going to use the first method where we simplify the numerator and denominator separately, then perform the main division. So we have 5 over 6 plus 1/2 over 5 over 8 plus 3/4. So we'll simplify again the numerator and denominator separately. If I look at the numerator of the complex fraction, I have 5, 6 plus 1/2. The LCD for these two fractions would be 6. So I would multiply 1/2 by 3 over 3 so that I can have a denominator of 6. So this would end up being 5 over 6 plus 1 times 3 is 3 over 2 times 3, which is 6. So we get 5, 6 plus 3, 6. And of course, 5 plus 3 is 8 over the common denominator of 6. Now, in the denominator of the complex fraction, we have 5/8 plus 3/4. The LCD here would be 8. So I can multiply this fraction by 2 over 2. And so I'd have 5/8 plus 3 times 2 is 6 over 4 times 2, that's 8. So 5 plus 6 would be 11 over the common denominator of 8. So we have 8/6 over 11/8, or 8/6 divided by 11/8, however you want to think about that. Let's just erase this and get a little room going. So again, 8/6 divided by 11/8. So all we need to do now is divide two fractions. 8/6 is going to stay the same. And we're going to multiply by the reciprocal of 11/8. So that would be 8/11. And if we look to cross cancel here, I know I can cancel a factor of 2 between 8 and 6. Right? 6 divided by 2 would be 3. 8 divided by 2 would be 4. That's all I can really cancel. So now we would just multiply. 8 times 4 is 32. And 3 times 11 is 33. So we'll end up with 32 over 33 as our answer. Hello and welcome to Pre-Algebra Test Section 3 on complex fractions. So we want to simplify each complex fraction. And we're just going to be looking at one problem for this video. So our problem is 5, 6 minus 3 over 2/5 plus 9 minus 1/3. So I'm going to start out in the numerator here. And I'm just going to work on it down here. So I'd have 5, 6 minus 3. And because I'm working with fractions here, I'm going to write 3 as 3 over 1. Just make everything nice and convenient. Now I can just think of everything as a fraction. Now, in order to do subtraction with fractions, I have to have a common denominator. Because this is a 1 here, I can simply multiply by 6 to get a common denominator with 5, 6. Now, because I multiply by 6 in my denominator, I need to also do the same thing with the numerator. So essentially, I'm going to multiply 3 over 1 by 6 over 6 so that we can have a common denominator. So we're going to end up with 5, 6 minus 3 times 6 is 18 over 1 times 6, which is 6. So now that we have that common denominator, I can just write that in my answer. And I'm just going to perform the operation using the numerators now. What is 5 minus 18? Well, we can think about this using addition with integers, right? If I had 5 plus negative 18, we all know how to do this operation at this point. We would use the sign of the number with the larger absolute value. So in this case, that's negative 18. So the answer is going to be negative. And then we would subtract the larger absolute value minus the smaller. So I would do 18 minus 5, that's 13. So we'd end up with a negative 13 as our answer. So I'm just going to throw a negative 13 in there. And so now we have simplified the numerator of our complex fraction. So let's go back up to the top. And we're going to write negative 13 over 6 up here. And now I'm going to focus on the denominator of the complex fraction. So we have 2/5 plus 9, and I'm going to write that as 9 over 1, minus 1/3. So we need to get a common denominator going, and the best we can do for the LCD here is going to be 15. All right, I have a 5, that's a prime number. I have a 1, and then I have a 3. 3 is a prime number. Really, the best I can do is 5 times 3, or 15. So I'm going to take 2/5 and multiply that by 3 over 3. And then I'm adding, I have 9 over 1. I'm going to multiply that by 15 over 15. And then I'm subtracting, I have 1/3. I'm going to multiply that by 5 over 5. Let's scroll down, get a little room going. So 2 times 3 is 6. And that's going to be over 5 times 3, that's 15. And plus 9 times 15. Really kind of a mental way to do this is 9 times 10, that's 90. Plus 9 times 5, that's 45. So that's going to give you 135. And all I did, not to kind of get off topic, but all I did was really just take 15 and make it into 10 plus 5. And then I just used my distributive property in my head. 9 times 10 is 90, plus 9 times 5, that's 45. And those are easy to add in your head, right? If I had 100 plus 45, that'd be 145. Take 10 away from that because I only had 90, that's 135. Okay, of course, after that, we have 1 times 15, and that's 15. And then minus, we have 1 times 5, that's 5, over 3 times 5, that's 15. We're going to work left to right because we have addition and we have subtraction. Order of operations tells us to work left to right. So I'm going to do 6 plus 135 first. That's going to give me 141. And then I'm going to subtract away 5, and that's going to give me 136. So this is going to be 136 over 15. So let's erase everything, and we're going to go back and put this as our simplified denominator. Okay, so again, 136 over 15. So now all we need to do is perform the main division. So we have negative 13 over 6, and we're multiplying this by the reciprocal of 136 over 15. So that would be 15 over 136. Now, what can we cancel here? As I see that we have a common factor of 3 between 15 and 6. So 15 divided by 3 would be 5. 6 divided by 3 would be 2. Now, what about between negative 13 and 136? Well, forget about the fact that this is negative for a minute. Is 136 divisible by 13? Because 13 is a prime number. So let's try that real quick. 136 divided by 13. 13 goes into 13 once. 1 times 13 is 13. And at this point, you can stop and say, no, it's not. Right? You can already see that you're going to have a remainder. But just for the sake of completeness, we can continue. Subtract here and get 0. Bring down the 6. 13 does not go into 6, so I'd put a 0. 0 times 13 is 0. Subtract and get 6. So really the answer here is 10 with a remainder of 6. And so we know that we can't do anything else with this fraction because 136 is not divisible by 13, and 13 is a prime number. So we can just go ahead and say that the answer here is going to be negative 13 times 5, which is negative 65, over, and then we have 2 times 136, which is 272. So our final answer here is going to be negative 65 over 272. Hello and welcome to Pre-Algebra Test Section 4 on complex fractions. So we want to simplify each complex fraction using the LCD method. So if we look at this complex fraction, we have 1/2 plus 3/8 over 3/4 plus 1/3. So for the LCD, remember this is the least common multiple, or the LCM, of all the denominators. So you have 2, you have 8, you have 4, and you have 3. So when we think about 2, that's prime, we just put it in. 8 is 3 factors of 2, so I would put another 2 factors of 2 in here. 4 is 2 factors of 2, we got that covered, and then 3 is prime, so we can throw that in there. So we would basically have 8 times 3, or 24, as our least common denominator here. So basically what I'm going to do is I'm going to multiply the numerator of the complex fraction by 24. And I'm going to also multiply the denominator of the complex fraction by 24. Now if I'm multiplying by 24 over 24, I'm essentially multiplying by 1, and I'm not changing the value of the fraction. So let's erase this real quick. So to multiply, we use the distributive property. 24 times 1/2, that's the same thing as saying, what is 24 divided by 2? That's going to be 12. Then plus, you'd have 24 times 3/8. So 24 times 3/8. 24 divided by 8 is 3. Then 3 times 3 is 9. Then this is over. We're doing the same thing down here. We'll have 24 times 3/4. So 24 times 3/4. 24 divided by 4 is 6. 6 times 3 is 18. So this will be 18. And then plus. Next you'll have 24 times 1/3. That's the same thing as saying, what is 24 divided by 3? And that's 8. So you'll have 12 plus 9, that's 21. Over 18 plus 8, that's 26. So is there anything we can do to simplify this fraction? 21 is 7 times 3, and 26 is 13 times 2. No factors in common, so 21 over 26 is our final answer. Hello and welcome to Pre-Algebra Test Section 5 on complex fractions. So we want to simplify each complex fraction using the LCD method. And we have 3/5 minus 1/3 plus 5/6 over 4/5 plus 1/5 plus 2/3. So to use this method, essentially all we need to do is find the LCD for all the denominators involved. So the LCD is going to be the least common multiple of 5, 3, and 6, right? Because that's all we have. We have a 5, these are 5s, a 3, that's a 3, and then a 6. So 5 is prime, 3 is prime, and 6 is 2 times 3. So I just need to put a 2 in there. 5 times 3 is 15, 15 times 2 is 30. So once we have this, basically all we're going to do is multiply the numerator of the complex fraction by 30 and the denominator of the complex fraction by 30. And you can think about why this is legal. I'm multiplying by 30 over 30, which is essentially 1. So let's see what we're going to get here. If I multiply 30 times 3/5, 30 times 3/5, 30 divided by 5 is 6, 6 times 3 is 18. Then minus, next you're going to have 30 times 1/3. That's the same thing as saying, what is 30 divided by 3? That's 10. Then plus, next we have 30 times 5 over 6. 30 times 5 over 6. 30 divided by 6 is 5. 5 times 5 is 25. And the denominator, I'm basically doing the same thing. I'm going to have 30 times 4/5. So I'd have 30 times 4/5. 30 divided by 5 is 6. 6 times 4 is 24. Then plus, next we're going to have 30 times 1/5. And that's the same thing as dividing 30 by 5. That's going to be 6. And then plus, next we have 30 times 2/3. So 30 times 2/3. 30 divided by 3 is 10. 10 times 2 is 20. And I'll continue down here. 18 minus 10 is 8. Then 8 plus 25 is 33. And this is over. 24 plus 6 is 30. Plus 20 is 50. So we get 33 over 50 as our answer. 33 is 3 times 11. 50 is 5 times 2 times 5. Not really anything I can simplify between the numerator and denominator. So this is my final answer. Again, 33 over 50. Hello and welcome to Pre-Algebra Practice Set number 39. In this video, we're going to look at some additional practice problems for our lesson on decimal fractions. So we want to write each as a decimal fraction. So we start out with 0.25. So to do this is easy. Basically what we want to do is write the part that occurs after the decimal point in our numerator. So if we have 0.25, 25 goes in the numerator. Then for our denominator, it's going to be a 1, followed by the same number of zeros as we have decimal places. So if we look at this here, when we talk about decimal places, we're talking about what occurs after the decimal point. I have one decimal place here, right, with that 2 in it. Then I have another decimal place here with the 5 in it. So I have two decimal places. And so when I write my fraction here, I'm going to have 2 zeros behind the 1. So 0.25 is the same thing as 25 over 100. All right, for the next one we have 0.987. So again, I'm going to take this part right here that occurs after the decimal point, and I'm going to put that in my numerator. So I'm going to have 987 in the numerator. And then for my denominator, I have a 1 followed by the same number of zeros as I have decimal places. So if I look, I have 1, 2, 3 decimal places, 3 decimal places. And so I'm going to have 3 zeros. 1, 2, 3. So we end up with 987 over 1,000 as our answer. Okay, what about 0.1? Well, again, I'm going to take this part right here that occurs after the decimal point, and I'm going to write it in the numerator. So I'm just writing a 1. And then it's over a 1, followed by the same number of zeros as we have decimal places. We can see that we have 1 decimal place here. So I'm going to put 1 0 after the 1, and I end up with 1 over 10, or 1/10. All right, what about 3.92? Well, we have a whole number here that's not 0. So I'm going to go ahead and write that to start. And then for my fraction part, I take what occurs after the decimal. In this case, that's 92 or 92. Put that in my numerator. For my denominator, I write a 1 followed by a 0 for every decimal place we have. So we have 1, 2 decimal places, 2 decimal places. So we'd put 2 zeros here. So we get 3 and 92 hundredths, or 3 and 92 over 100. What about 15.73617? So I have a whole number part that's not 0, so I'm going to write that. So we're going to write 15. And then for the fraction part, this right here that occurs after the decimal point, that's going to be my numerator. So 73617, or 73,617. And then for the denominator, I put a 1 followed by a 0 for every decimal place that I have. So I have 1, 2, 3, 4, 5 decimal places. 5 decimal places. So this is going to get 5 zeros. 1, 2, 3, 4, 5. And put a comma in there. So we get 15 and 73,617 over 100,000. All right, next let's look at 4.2551892. So again, if I have a whole number part, I'm going to write that. So that's going to be 4. And then for my fraction part, basically I'm going to take this part right here that occurs after the decimal point, put that in the numerator. So 2551892. And I'm going to put this over a 1 followed by a 0 for every decimal place that I have. So if I look, I have 1, 2, 3, 4, 5, 6, 7 decimal places. So we get 1, 2, 3, 4, 5, 6, 7 zeros there, comma, comma, and we end up with 10 million as the denominator. So we get 4 and 2,551,892 over 10 million. All right, now we want to write each decimal fraction using decimal notation. So we're going to start out by looking at 3 over 100. And again, if I look at 3 over 100, basically the shortcut to do this is just write the numerator down and put a decimal point there. And basically for every 0 that you have in your denominator, you're moving that decimal point to the left. So if I have 2 zeros in my denominator, I'm moving the decimal point 1. And I need to add a 0 in here, and then 2 places to the left. So I'm going to end up with 0.03 as my answer. All right, next we're going to look at 7 over 1,000. Again, kind of the shortcut to do this, I have 7. I'm going to put a decimal point after. And then I have 1, 2, 3 zeros in the denominator. So I'm going to go 1, put a 0 here, 2, put a 0 here, 3 places to the left. So I'm going to end up with 0.007 as my answer. Next we have 21 over 100. So again, I'm going to put 21 down. I'm going to put my decimal point, and I have 2 zeros in the denominator. So this is going 1, 2 places to the left. So I'm going to end up with 0.21 as my answer. Now I have 9 and 15 over 1,000. So I'm going to write this whole number first. Then I'm going to write my decimal point. And then I'm going to think about this separately. So I have 15 over 1,000. So what I'm going to do here is I'm going to write 15 and then a decimal point. And I have 1, 2, 3 zeros in the denominator. So I'm going to go 1, 2, put a 0 in, 3 places to the left. So I get 0.015. Now I already put my decimal point down. So really all I need is to put the 0, the 1, and the 5. So I end up with 9.015 as my answer. Let's look at 11 and 27 over 10,000. So again, I'm going to write my whole number part, which is 11. Then I can put my decimal down and just think about the 27 over 10,000 separately. So I'm going to go ahead and write 27, put a decimal point at the end, and I've got 1, 2, 3, 4 zeros down here. So I'm going to go 1, 2, 3, 4 places to the left. So we'd have 0.0027. So after the decimal point, I basically have 0027. So 11.0027. And so that's my answer. All right, let's take a look at one final problem. We have 13 and 55 over 100. So I'm going to write 13 down, put my decimal point, and then for 55 over 100, I'm going to write 55, put my decimal point at the end. I've got 2 zeros and 100, so this goes 1, 2 places to the left. They give me 0.55. Again, I already have my decimal point written, so I just write what's after it. So I just write 5, 5. So we end up with 13.55 as our answer. Hello and welcome to Pre-Algebra Test Section 1 on decimal fractions. So we want to write each as a decimal fraction. We're going to start out with 0.37. So the procedure to do this is really quite simple. And actually there's kind of a shortcut. Basically what I would do is I would look at the part that occurs after the decimal point. So we have the 37 there. We're going to put that in our numerator. So we'll have 37 in the numerator. For our denominator, we're going to have a 1 followed by the same number of zeros as we have decimal places here. So when we talk about decimal places, we're talking about what occurs after the decimal point. So we have a 3 here, that's 1 decimal place. Then we have a 7, that's another decimal place. So we basically have 2 decimal places here. And so in my denominator, when I'm building this decimal fraction, I'm going to have 2 zeros. So 0.37 or 0.37 is equal to 37 over 100. All right, next we have 2.125. Now, when we have a whole number out here to the left of the decimal point that's not 0, we'll go ahead and write it because we're going to end up building a mixed number here. Now, the procedure for building the fraction part is going to be the same. I take what occurs after the decimal point, I put that in the numerator. So in the numerator, I'll have 125. In my denominator, I'll have a 1, followed by the same number of zeros as I have decimal places. So we have 1, 2, 3 decimal places. 3 decimal places. And so we're going to end up with 3 zeros after that 1. So we get 2 and 125 over 1,000 as our answer. Hello and welcome to Pre-Algebra Test Section 2 on decimal fractions. So we want to write each as a decimal fraction, and we have 0.0984. So basically the first thing you're going to do is take what occurs after your decimal point, so in this case it's 0.984, and put that in your numerator. So 0.984. Now, since we don't have a decimal involved here, I know we could write a decimal here if we wanted to, but since we don't have a decimal point involved here anymore, we can erase this 0. It's not adding any value to the number. Really, my numerator is going to be 984. All right, if I have the number 984, it's the same thing as if I have the number 0, 0, 0, 984. These zeros are not adding any value to the number. So again, we write that as 984 for our numerator. For our denominator, we put a 1, and we follow that up with a 0 for every decimal place that we have. So if we look here, we have 1, 2, 3, 4 decimal places. 4 decimal places. So that means we get 4 zeros behind this 1. 1, 2, 3, 4. So we end up with 984 over 10,000. All right, next we have 8.1175. So I take this whole number part here, 8, and write it as a whole number for the mixed number we're going to build. Then I take this part right here, the 1,175. I'll write that as the numerator for the fraction part of the mixed number. Then for the denominator, I'm going to have a 1 followed by, again, the same number of zeros as I have decimal places. So we have 1, 2, 3, 4. Again, 4 decimal places. So I'm going to have 4 zeros here. 1, 2, 3, 4. So we end up with 8 and 1,175 over 10,000. Hello and welcome to Pre-Algebra Test Section 3 on decimal fractions. So we want to write each as a decimal fraction. We start out with 6.2275. So again, if you have a number that's not 0 that occurs to the left of your decimal point, you're going to go ahead and write that as the whole number for the mixed number that you're going to form. Now this part that occurs after the decimal point, in this case it's 2,275, that's going to go in the numerator. And then your denominator is a 1 followed by a 0 for every decimal place you have. So we have 1, 2, 3, 4 decimal places. 4 decimal places. So we're going to have 4 zeros behind this 1. 1, 2, 3, 4. So we end up with 6 and 2,275 over 10,000. All right, for the last one, we have 13.118552. So we have something that occurs to the left of the decimal points. That's this 13 here. So we're going to go ahead and write that. That's going to be the whole number for the mixed number we're building. And then we take what occurs after the decimal point. In this case, it's 118,552. We're going to write that as our numerator for the fraction part of the mixed number. And then in the denominator, we have a 1 followed by a 0 for every decimal place we have. So we have 1, 2, 3, 4, 5, 6 decimal places. 6 decimal places. And so what that means is we're going to have 6 zeros here. 1, 2, 3, 4, 5, 6. So we get the number 1 million in our denominator. And so our answer here is 13 and 118,552 over 1 million. Hello and welcome to Pre-Algebra Test Section 4 on decimal fractions. All right, so we want to write each as a decimal. And we start out with 6 over 10 or 6 tenths. Basically, this is pretty easy. All you're going to do is take the number in the numerator. So in this case, it's 6. Go ahead and write that and put a decimal point to the right of it. Now, I'm going to move that decimal point one place to the left for every 0 in my denominator. So for 10, I just have 1 0. So that means my decimal point goes one place to the left. And I'm going to end up with 0.6 as my answer. Next, I have 3 4/100ths, or 3 and 4 over 100. So in this case, I kind of have a mixed number here. So when that happens, the whole number part just gets rewritten. So we're going to have 3. And then basically, we'd have a decimal point here. You can go ahead and write it now, or you can write it after you figure out what 4 over 100 is using decimals. So 4 over 100, again, I'm just going to write 4, put my decimal point after 4, and then I'm moving this decimal point 2 places to the left because I have 2 zeros down here. So 1, I'm going to put a 0 in, and then 2, and end up with 0.04. Just drag that up here and put it after the 3. So 3.04 is going to be my answer. Hello and welcome to Pre-Algebra Test Section 5 on decimal fractions. All right, we want to write each as a decimal. And we're starting out with 25 and 3 over 10,000. So if you have a mixed number like this, just go ahead and take your whole number part, which in this case is 25, and just rewrite that to start. So after 25, you're going to have your decimal point, and then you're going to have this value here. So let's go ahead and put 3 over 10,000 down here, and we'll just kind of work on it separately. So basically I start out by taking 3, the number in the numerator, and writing it. And I put a decimal point to the right of it. And then I move it one place to the left for every 0 in the denominator. We have 1, 2, 3, 4 zeros in 10,000. So this is going to go 4 places to the left. So 1, 2, 3, and finally 4 places to the left to give me 0.0003. So I'm just going to bring that up here. So we'd have 25.0003 as our answer. All right, so lastly we have 459 over 1 million. So again, I'm going to rewrite that numerator over here, 459. I'm going to put my decimal point at the end, and I'm moving that decimal point one place to the left for every 0 in the denominator. So I've got 1, 2, 3, 4, 5, 6 zeros here. So this is going 1, 2, 3, 4, 5, 6 places to the left. So I'll end up with 0.000459. Hello and welcome to Pre-Algebra Practice Set number 40. In this video, we're going to look at some additional practice problems for our lesson on comparing and rounding decimals. All right, so we're going to start out by looking at some problems where we want to state the place value for each digit in the number. And for our first one, we have 0.284. So we're just going to feed this into the place value chart, and then we're going to write out the place value for each digit. So I don't need to worry about this 0. It would be in the ones place, but it doesn't add any value to the number. We're just going to put the stuff after the decimal point. So we're going to start out with the 2 that's in the tenths place. Then we have an 8 in the hundredths place. Then we have a 4 in the thousandths place. So kind of to write this out, again, the 2 is in the tenths place. The 8, again, is in the hundredths place. And then lastly, again, this 4 is going to be in the thousandths place. All right, let's take a look at another one. We have 0.9135. So again, I'm not going to worry about the 0. Again, it would be in the ones place, but we're just putting it in this number because a lot of times you want to put a 0 in your ones place if your number doesn't have a whole number part, right? It just brings clarity to that decimal point there. So the first number after the decimal point is a 9. That's going to go in my tenths place. Then we have a 1 in the hundredths place, a 3 in the thousandths place, and then lastly a 5 in the 10,000ths place. So let's write this out. So again, I have a 9 in the tenths place. I have a 1 in the hundredths place. A 3 in the thousandths place. And then lastly, this 5 is in the 10. And then we want to put a hyphen and then thousandths place. All right, for the last one, we have 7.2175134. So we actually have a whole number here. We have a 7 that's in the ones place. We have our decimal point, and then we have a 2 in the tenths place, a 1 in the hundredths place, a 7 in the thousandths place, a 5 in the 10,000ths place, a 1 in the 100,000ths place, a 3 in the millionths place, and then lastly a 4 in the 10 millionths place. So again, just the 7 is going to be in the ones place. The 2 is going to be in the tenths place. The 1 is in the hundredths place. The 7, again, is in the thousandths. Then the 5 is in the 10,000ths. The 10,000ths. And we're getting a little congested here, but we're going to manage. Then the 1 is in the 100,000ths. The 100,000ths. Then we have a 3 in the millionths. This is in the millionths. And lastly, we have a 4 in the 100 millionths. This is in the 100 millionths. And I can make this e a little bit better. All right, now we're going to look at some problems that deal with comparing decimals. So we want to replace each question mark with the less than, greater than, or equal to sign. So we have 0.513 question mark 0.53100. So let's stack these numbers on top of each other, and we're going to compare corresponding digits working from left to right until we find corresponding digits that are different. So we have 0.513, 0.53100. So starting at the left, I have 0, 0, I have 5, 5, and then I have 1 and 3. So here's where we have different corresponding digits. When I say corresponding digits, I mean they're each in the hundredths place for their given number. Now, what you look at is this number is a 1, this number is a 3. 3 is greater than 1. So this digit 3, since it's bigger than this digit 1, belongs to the bigger number, right? So once you get to two numbers that are in a corresponding position in terms of place value, the larger digit belongs to the larger number. So we can go back and say that 0.513 is the smaller number, so it's less than 0.531. And I don't need these two zeros here. Remember, that doesn't add any value to the number. If it makes you more comfortable, you can write them, or you can even put more behind it. It doesn't really matter because in the end, it's the same number as 0.531. Let's take a look at 8.2751, question mark 8.2731. So again, I'm going to stack these numbers on top of each other, line them up by place value, and we're going to compare digit by digit, working left to right. So 8 and 8 are the same, 2 and 2 is the same, 7 and 7, that's the same. Now we have 5 and we have 3. So 5 is greater than 3, so that tells me that this number right here is the larger number. So we would write 8.2751 is greater than 8.2731. And again, everything is the same up to the point where we get to the thousandths place. The thousandths place here has a 5. The thousandths place here has a 3. 5 is greater than 3, so that means that this number that contained the 5, 8.2751, is greater than 8.2731. Let's take a look at one final problem. So now we have 0.001375, question mark 0.004398. So again, I'm going to stack these numbers on top of each other. So 0.001375, 0.004398. And this one's pretty easy to look at because right away you can see that these are all the same, but you have a 1 and then you have a 4. 4 is obviously greater than 1, so this number right here is going to be greater. And if you just kind of erase the zeros for a second and just look at the numbers that are left, you can see that 4,398 would be bigger than 1,375. Well, everything up to that point was the same, so this is obviously going to be the bigger number. Let me just put our zeros back in, and we can go ahead and write our less than symbol here. 0.001375 is less than 0.004398. All right, now let's look at some problems that deal with rounding. So we want to round each to the nearest tenth. So all I want to do is find the digit in the tenths place to start, and that's going to be this 2, right? The digit right after that decimal point. So same rules as when we rounded whole numbers, one slight variation. This step is the same. I'm going to look at the digit to the right of the digit in the round off place. If it's 4 or less, basically I'm going to keep my digit in the round off place the same. If it's 5 or greater, I'm going to add 1 to the digit in the round off place. This falls in the category of 4 or less, so I'm going to keep that 2 the same. Now, when we worked with whole numbers, our next step was to replace every digit that followed the digit in the round off place with a 0. Let's go ahead and do that and see what happens. So we'd have 5.2, and then I have a 0 to replace the 1, a 0 to replace the 7, and a 0 to replace the 5. When you work with decimals, anything after the decimal, once I have a decimal point, after your last non-zero digit, you can add as many zeros as you want to the end of that number and not change the value. So this number right here is the same as if I did this. And I could just put as many as I want, it doesn't matter. Or I could erase every single zero after that too. It's still 5.2. So the last step when you actually round decimals, after you've taken care of your digit in the round off place as far as either adding 1 to it or keeping it the same, you just delete everything that follows. Right? You don't need to change it into a 0 because that will not change the value of the number. All right, now we're going to work on 3.0657. So the 0 is the digit in the tenths place. I'm looking at the 6, the digit to the right, to make the decision. 6 falls in the category of 5 or greater, so I add 1 to the digit in the tenths place. So 0 plus 1 is 1, so I'd have 3.1, and I just delete everything that follows. So 3.1 is my answer. Again, the reason for me deleting this stuff, if I change the 6, the 5, and the 7 to a 0, it's the same as if I just had 3.1, right? I have not changed the value of the number by putting in these 3 zeros, so we can just erase them. All right, now we want to round each to the nearest hundredth, and we're going to start out with 16.9673. So the digit in the hundredths place would be this 6 here. And again, I'm looking at the digit that follows. In this case, that's a 7. 7 falls in the category of 5 or greater, so I add 1 to the digit in the round off place, so I'd have 16.97, right? 6 plus 1 is 7, and then you can just delete everything that follows, so this would be my answer. All right, lastly, I have 0.009201. So again, if I look for the digit in the hundredths place, this is the tenths, this is the hundredths right here. So look at the digit that follows. The 9 falls in the category of 5 or greater, so I add 1 to my digit in the hundredths place. So 0 plus 1 is 1, so I'd have 0.01. And then I delete everything that follows that hundredths place. And so 0.01 is my final answer. Hello and welcome to Pre-Algebra Test Section 1 on comparing and rounding decimals. So we just want to state the place value for each digit in the number. So we're going to start out with 0.397. And what we're going to do is we're going to feed this number into our place value chart. And then we're going to write out the place value for each digit of the number. So you can start out by putting 0 in the ones place, but really we're putting that 0 there just for clarity. And that's often done when you have a decimal and some numbers after the decimal, but nothing out in front, right? So no whole number involved. So again, you could put the 0 here or you could not, doesn't really matter. And after that, you have a 3 that immediately comes after that decimal point. So that's going to be in the tenths place, then a 9 in the hundredths place, and a 7 in the thousandths place. So let's label this on the number. So again, the 3 is in the tenths place. The 9 is in the hundredths place. And then lastly, the 7 is in the thousandths place. All right, for the next one, we have 1.1534. So in this case, we do have a whole number involved. We have that 1, and that's going to go in the ones place. It's to the left of the decimal point. And then right after the decimal point, to the right of it, we have a 1 that goes in the tenths place, a 5 that goes in the hundredths place, a 3 that's going to go in the thousandths place, and then a 4 that's going to go in the 10,000ths place. So let's write this on the number. Again, the 1, the leftmost 1, is in the ones place. Then this one here to the right of the decimal point, that's in the tenths place. Then this 5 is in the hundredths place. The 3 is going to be in the thousandths place. And then lastly, this 4 is going to be in the 10,000ths place. So I'm going to write 10, a hyphen, and then thousandths, again, place. Okay, for the final one, we have 0.658513. And again, if you want to put a 0 in the ones place, you can. Not really necessary for this exercise. So after our decimal point, we have a 6 that's going to go in the tenths place, a 5 that's going to go in the hundredths place, an 8 that's going to go in the thousandths place, a 5 that's going to go in the 10,000ths place, a 1 that's going to go in the 100,000ths place, and then lastly a 3 that's going to go in the millionths place. Now my screen's going to get a little crowded writing all this stuff in, but I'm going to do the best that I can. So this 6 is in the tenths place. the 5 is in the hundredths place. The 8 is going to be in the thousandths place. The 5 is going to be in the 10,000ths place. The 1 is going to be in the 100,000ths place. And then lastly, the 3 is going to be in the millionths place. Hello and welcome to Pre-Algebra Test Section 2 on comparing and rounding decimals. So we just want to replace each question mark with the less than, greater than, or equal to symbol. All right, so we have these two decimals here. We have 0.3915, question mark 0.3859. Kind of the easiest way to do this is to stack the numbers on top of each other, make sure they'll line them up by place value. So we're going to line up the decimal points. So we're going to do 0.3915 and then 0.3859. So we start out all the way to the left and we look at corresponding digits. And what I mean by that is we're looking at digits that have the same place value, but they're in different numbers, right, that we're comparing. So I look at this 0 and this 0. They're the same, so I just keep moving to the right when that happens. Look at this 3 and this 3. They're the same. Look at a 9 and then an 8. So we have different numbers here. Different numbers here. Now 9 is greater than 8. So that tells me that 0.3915 is going to be the larger number. Okay? We move to the right until we hit different corresponding digits, and then the larger digit belongs to the larger number. So we would say that 0.3915, or if you want to, you could put a 0 out in front like I have here. Again, this would be the same either way, is going to be greater than 0.3859, or again, you could put 0.3859. And again, the reason for this is because this 9 here, that's in the hundredths place, is larger than this 8 that's in the hundredths place over here. Up to that point, starting from the left and going to the right, everything's the same. You have a 0 here and a 0 here. You have a 3 in the tenths place here and a 3 in the tenths place here. But when you get to the hundredths place, this is a 9 and this is an 8. So that tells me that this number is going to be larger because this digit 9 is larger than this digit 8. Let's take a look at another one. We have 0.22513, question mark, 0.22315. So again, I'm going to stack these numbers on top of each other. And at this point, after you do enough practice, you can kind of eyeball it and see, okay, everything is the same until I get right here. I have a 5 here and a 3 here. So that tells me that the number that has the 5 in the thousandths place is going to be bigger than the number that only has a 3 in the thousandths place. Right? Everything working from left to right up to that point is the same. So that tells me that 0.22513 is greater than 0.22315. All right, let's take a look at another one. We have 0.87015, question mark 0.871. Now, don't let this fool you. A lot of students will right away say that, okay, well, this number must be bigger because it has more digits. That's not necessarily true. So we'll go 0.87015 and then 0.871. Now, if it makes you feel more comfortable, you can always put 2 zeros at the end here so that the number of digits you have in each case are matching up. Again, if you want to leave them off, it doesn't matter because it doesn't change the value of the number. So again, we start out all the way at the left and we work our way to the right. So the same, the same, the same. And then here we have a 0, here we have a 1. So what this tells me is that in the thousandths place, for this number I have a 0, and that's going to be smaller than the 1 that I have in the thousandths place for this 0.871. So in fact, this number with fewer digits is going to be larger. So this 0.871 is larger than 0.87015. So we're going to put a less than symbol in here. And again, let me just read this. 0.87015 is going to be less than 0.871. And again, that's because this digit right here, this 1, in the thousandths place for this number is larger than this 0 in the thousandths place for this number. and everything to the left of those numbers in each case is the same. Hello and welcome to Pre-Algebra Test Section 3 on comparing and rounding decimals. So we want to replace each question mark with the less than symbol, the greater than symbol, or the equal symbol. And we're going to start out with 4.65153, question mark 4.67153. So again, you want to stack these numbers on top of each other and line them up according to their place values. So in other words, I can just put 4.65153 on top, and then I can put 4.67153 on the bottom. And notice how I lined everything up by place value. So I'm going to start out all the way to the left, and if everything's the same, I'm just going to work my way to the right. So I have a 4 here and a 4 here, a 6 here and a 6 here, and then finally I have something that's different. I have a 5 and then a 7. So when you have a larger digit in a corresponding position and everything to the left is the same, it's going to be for the bigger number, right? So that 7 that's in the hundredths place here tells me that it's a bigger number than this number here that has a 5 in the hundredths place, right? Because everything to the left is the same. So 4.65153 is smaller or less than 4.67153. Again, everything up to this point is the same. When we get to the digit in the hundredths place, here it's a 5, here it's a 7. 7 is bigger than 5, so that tells me that this whole number here is bigger. Okay, next we're looking at 3.213, question mark 3.2130. So again, line up the numbers by place value. So 3.213, 3.2130. So this is the same, this is the same, this is the same, this is the same. And then here I have a 0. And remember, after this 3, I can put as many zeros as I want. So I can do this, and I can do this as well. And what I find is I have the exact same number. So pay attention for trick questions like that, because you'll probably see something like that on a test. Right? These two are the same. I just put a 0 at the end there. And remember, I'm allowed to do that without changing the value of the number. So these two are going to be equal. 3.213 is equal to 3.2130. Okay, for the final problem, we have 15.9175, question mark 15.91753. So again, 15.9175, 15.91753. So this one's really easy to just kind of eyeball and see because everything is the same up till you get to this point. So I have a 3 here and I don't have anything here. But remember, I could write a 0 there if I want to make it easy to compare. 3 is greater than 0, so this is the larger number. So 15.9175 is smaller or less than 15.91753. Hello and welcome to Pre-Algebra Test Section 4 on comparing and rounding decimals. All right, so we want to round each to the nearest tenth and hundredth. So we're going to start out with 6.2515. So to round to the nearest tenth, we need to find the digit in the tenths place. So that's going to be this digit right here. That 2 is in the tenths place. So then we're looking at the digit immediately after to make our decision. Remember, if it's 4 or less, we leave the digit in the round off place as is. If it's 5 or larger, like we have in this case, we add 1 to the digit in the round off place. So I would have my 6. This digit's unaffected because it's to the left of the round off place digit. My decimal point, add 1 to 2, I get 3. And then every digit that follows, remember when we're rounding whole numbers, we change them to zeros. But when we round decimals, we can just delete them, right? Because if I put 3 zeros here, it doesn't change the value of the number. 6.3 is the same as 6.3000. So I can just get rid of these. Now to round to the nearest hundredth, let me just erase this. Now we're looking at the digit in the hundredths place, that's this 5, and we look one more digit over to the right to make our decision. So the 1 falls in the category of 4 or less, so that means the digit in the round off place is going to stay unchanged. So we would have 6.25, and then we would delete everything that follows, right? The 1 would get deleted, and so would the 5. Again, if I was following the procedure for whole numbers, I would change the 1 into a 0 and the 5 into a 0. But again, because we're working with decimals here, those two zeros don't add any value to the number. so we can just delete them. Okay, for the last one, we have 3.91752. And again, we're rounding to the nearest tenth, and we're rounding to the nearest hundredth. So to round to the nearest tenth, I'm going to find the digit in the tenths place. That's this 9 here. And I'll look one digit to the right. So one digit to the right, I have a 1. 1 falls in the category of 4 or less. So I leave my digit in the round off place as is. So we'd have 3. That's a digit to the left of the 9, so we leave that unchanged. A decimal point, and then 9 again is going to be unchanged. And then everything that follows is just going to get deleted. So we'd end up with 3.9 as our answer. Now let's erase this and let's look at the scenario where we're rounding to the nearest hundredth. So now I'm looking for the digit in the hundredths place, and that's going to be this 1 here. And to make my decision, I look at the digit immediately to the right, so that's the 7. 7 falls in the category of 5 or greater, so I'm going to add 1 to this digit in the round off place. So I'd have 3.9. 1 plus 1 would be 2, and then everything after can be deleted. So 3.92 would be this number right here, 3.91752, rounded to the nearest hundredth. Hello and welcome to Pre-Algebra Test Section 5 on comparing and rounding decimals. All right, so we want to round each to the nearest thousandth and 10,000th. So for the first problem, we have 0.62175. And so to round to the nearest thousandth, I need to find the digit in the thousandths place. So this is the tenths place, the hundredths place, and then this is going to be the digit in the thousandths place. So then I'm always looking at the digit one place to the right. In this case, it's a 7. And again, if that digit is 4 or less, we leave the digit in the round off place unchanged. If it's 5 or greater, we add 1 to the digit in the round off place. 7 is in the category of 5 or greater, so I'm going to add 1 to the 1, the digit in the round off place. So we have 0.62, 1 plus 1 is 2. And then I'm going to delete everything that follows. And you might ask, why is that the case? Well, when we're rounding whole numbers, you'll recall that after we do this step, we change 7 into a 0 and 5 into a 0. Here that's not necessary because these zeros don't add any value to the number, right? After that 2, I can put as many zeros as I want. It doesn't really matter. It's the same as if I erase all of them, right? You get 0.622 either way. Now, if we're going to round to the nearest 10,000th, what I'm going to do is now I'm going to look at my digit in the round off place being this 7, right? That's the 10,000ths place. And so for my decision, I move 1 digit over to the right. I'm looking at that 5. 5 falls in the category of 5 or greater. So what I would do is add 1 to the 7. So I'd have 0.621. 7 plus 1 is 8. And then I'd cut the 5 off, right? I could change it into a 0, but again, if I put a 0 here, it doesn't add any value to the number, so I can just go ahead and erase it. All right, for the next one, we have 15.7200519. And again, we're rounding to the nearest thousandth and 10,000th. So the thousandths place is going to be right here. And the digit that follows is going to be a 0. So what's going to happen is, again, 0 falls in the category of 4 or less. So I leave this digit right here, the digit in the thousandths place, unchanged. But it happens to be a 0. So we're going to see that we'll have 15.72. Now I can put the 0 here, but really I don't need to because it doesn't change the value of the number. Really, I just have 15.72. After this 2, I could put as many zeros as I want, and the number's still 15.72, right? I'm not changing the value. So this would be the result for rounding to the nearest thousandth. All right, now the next thing we want to do is round to the nearest 10,000th. So that's going to be right here, right? This is the 10,000ths place. And now I'm looking 1 digit to the right, and I'm looking at that 5. 5 falls in the category of 5 or greater. So I'm going to add 1 to this digit in the round off place. So I'll have 15.720. 0 plus 1 is 1. And then everything that follows, the 5, the 1, and the 9, I can just delete it. Again, not to keep repeating myself, but I could change them each into a 0, but they don't add any value to the number, so I can just erase them. So 15.7201 would be this number rounded to the nearest 10,000th. Hello and welcome to Pre-Algebra Practice Set number 41. In this video, we're going to look at some additional practice problems for our lesson on adding and subtracting decimals. All right, so we just want to perform each operation. And we're going to start out with an addition problem. We have 0.94 plus 0.15301. So remember, these zeros that occur to the left of the decimal point, they're really just for clarity. Kind of to draw attention to the fact that we have a decimal point there. We really don't need to include them when we start doing our addition. So to add these two decimals, basically what we want to do is just stack the numbers on top of each other and line them up, make sure their decimal points are lined up. So I'm going to put 0.94 on top. And on the bottom, I'm going to put 0.15301. And just like I do with vertical addition with whole numbers, I set everything up the same way. Nothing's really changed. Now, I want you to recall that when you're working with decimals, if I have a decimal point and I have a non-zero number, like let's say 7. After that 7, if I have nothing else behind it, I can put as many zeros as I want, and I'm not changing the value of the number, right? Again, this is after your decimal point. Now, if you want to use this to help yourself add, you can put some zeros in right here. It won't change the value of the number, and you'll have the same number of digits kind of in the top part and in the bottom part. Whatever you want to do, you can erase it and just bring the numbers down also. So let's do that. So the first thing I'm going to do is bring down the 1, then bring down the 0, then bring down the 3. Then next I have 4 plus 5, that's 9, and then 9 plus 1, that's going to be 10. Now I have to be very careful here. I'm going to put a 0 down, and I'm carrying a 1 up here. There's nothing up here really, so it just goes over here. But remember that you have to put your decimal point immediately down into the answer. It's got to go straight down, so that 1 goes kind of to the whole number part, right? It goes past where the decimal is, or to the left of the decimal. So our answer here is going to be 1.09301. And a good practice to get in, and I'm sorry I didn't do it when I started this problem, is before you even start adding, bring your decimal point down. And in the lesson I had a few where I just forgot to do it until the very end. Some students will make that mistake and they'll never bring down the decimal point and say, okay, this is 109,301. Forget they're working with decimals at all and say the answer is 109,301. Remember, you have to bring down that decimal point into the answer, and it's got to go straight down. Again, our final answer here is 1.09301. Okay, for the next one, we have 3.159 minus 0.648825. So because of subtraction, it matters what goes on top and what goes on the bottom. 3.159 is going to go on top, and then 0.648825 is going to go on the bottom. Put my subtraction sign out here, and this time I'm going to remember to bring this straight down before I start doing anything. Again, it doesn't matter when you do it. It's just better to do it when you start so that you don't forget. That's the main thing, is just don't forget to do it. Now, when we go to start subtracting, you'll notice that you have a little problem. Don't you need a number to subtract away 5? So what you want to do is, again, use that trick where you put some zeros at the end. Again, because I have a decimal point here and it's after that 9, I'm not adding any value to the number by putting zeros here. It's the same thing. So now I can go through and perform my subtraction. I've got to borrow, so I'm going to go all the way to the 9 and borrow from it. So the 9 is going to become an 8, this will become a 10, then a 9, this will become a 10, then a 9, and then this will become a 10. So now I can finally subtract. 10 minus 5 is 5, 9 minus 2 is 7, 9 minus 8 is 1, 8 minus 8 is 0, 5 minus 4 is 1, 1 minus 6 I need to borrow. So this will become 2, this will become 11, 11 minus 6 is now 5. I have my decimal point already written, and then I could just bring down this 2. So for my answer, I'm going to get 2.510175. Okay, let's take a look at an addition problem with 3 numbers. And nothing really changes. I'm going to stack these numbers on top of each other. I can do it in any order because it's addition. Addition is commutative. But I'm just going to follow kind of this order. We have 2.915 plus 0.816 plus 7.6401. I'm going to put 2.915 on top. I'm going to put 0.816 in the middle. And then I'm going to put 7.6401 on the bottom. And I think a lot of people, for convenience sake, will put the number with the most amount of digits on top and then kind of move down that way. Whatever makes you feel more comfortable. Again, it's addition, so you can do it in any order. And again, another thing is I can put some zeros here if I want, so that I have the same number of digits after my decimal point in each case, or I can take them off. It doesn't really matter. Now I'm going to remember to put my decimal point down into the answer this time because I always seem to forget. And then I'm just going to start adding. So bring down the 1. 5 plus 6 is 11. 11 plus 0 is 11. Put down a 1, carry a 1. 1 plus 1 is 2. 2 plus 1 is 3. 3 plus 4 is 7. 9 plus 8 is 17. Plus 6 is 23. Then I have 2 plus 2, that's 4. Plus 7 is 11. So we're going to get 11.3711 as our answer. So let's write this up here. 11.3711. All right, next we have 46.35 minus 17.7901. So we have our subtraction problem. Again, the order matters here. So I'm going to take the left part, which is 46.35, and put that on top. And then I'm subtracting away 17.7901. Again, I'm going to remember to bring down my decimal point in the answer. And I can't start subtracting yet. I want to put some zeros in there. Put some zeros in here because we're doing subtraction. And if you have fewer digits kind of in your top number, you're going to put some zeros in there just so you can do the subtraction. So I'm going to go all the way to the 5 so I can borrow. This becomes 4. This will become 10, then 9. Then this will be 10. Now I can do 10 minus 1, that's 9. 9 minus 0 is 9. Borrow from the 3 here. This will become 2. This will become 14. 14 minus 9 is 5. Then 2 minus 7, I need to borrow again. This will become 5. This will become 12. 12 minus 7 is 5. And 5 minus 7, I need to borrow one more time. This will become 3. This will become 15. 15 minus 7 is 8. 3 minus 1 is then 2. So I get 28.5599. So 28.5599. All right, so now we have some negatives involved. And what I'm going to tell you is that the same rules that you saw when you worked with integers are going to apply here. So the first thing I would notice here is that everything is a negative. If I'm adding 3 negative numbers, the result will be negative. So once I know that, all I need to do is work with the absolute values, right? So I can, in other words, just say this is 1.275 plus 6.25 plus 11.0909. Treat all these numbers as if they're positive and just add them all at the same time. When I'm done, I'll put it next to the negative symbol to say, hey, this is a negative number. So just go ahead and bring down the 9 to start. 5 plus 0 is 5. 7 plus 5 is 12. Plus 9 is 21. Put a 1 down, carry the 2. 2 plus 2 is 4. Plus 2 is 6. Plus 0 is still 6. And I forgot to bring down my decimal when I started. But again, as long as you do it before you end the problem, you'll be all right. So then moving over here, I have 1 plus 6, that's 7. Then plus 1. And kind of the way I wrote this, it's not very clear that that 1 is in that column. So let me kind of just scoot this over a little bit. And again, let me just kind of restart that. 1 plus 6 is 7. Plus 1 is 8. And then bring down the 1. That's going to give us 18.6159. But again, we had 3 negative numbers, so we already determined that the sign would be negative. So then once I attach that, we'll have negative 18.6159. All right, let's look at a final problem here. We have 30.94 minus a negative 73.81 minus 0.295. So the first thing I'm going to do is I'm going to rewrite this minus a negative as plus a positive. So 30.94 plus positive 73.81. And then we'll have minus 0.295. I'm going to work left to right. So I'm going to do this first. So 30.94 plus 73.81. I'm going to bring my decimal point down into the answer. 4 plus 1 is 5. 9 plus 8 is 17. Put a 7 down, carry the 1. 1 plus 0 plus 3 is 4. 3 plus 7 is 10. So I'd get 104. I'd get 104.75. 104.75. And then I'm subtracting away, again, 0.295. So again, we'll line this up by decimal point. So 104.75 minus, you have 0.295, so just 0.295. And I could put a 0 at the end here so that I can subtract. Cross this out and make it a 4. And put this as a 10. I'm just going to borrow there. 10 minus 5 is 5. And I need to borrow again. So I'll borrow from the 7. This will become 6. This will become 14. 14 minus 9 is 5. And then 6 minus 2 is 4. Forgot to bring down my decimal point, but I'll do it now. And then everything else can just come down. So 104 just comes down. So our final answer for this problem is going to be 104.455. Hello and welcome to Pre-Algebra Test Section 1 on adding and subtracting decimals. All right, so we just want to perform each operation. And we're going to start out with 36.541 plus 12.9042. So again, if you're adding decimals, all you need to do is use the same procedure that you would if you were adding whole numbers. Just make sure you line up the decimal points. So 36.541. I'm going to put that on top, and then 12.9042. I'm going to put that on the bottom. And just bring down the decimal point into the answer, and then just add like you normally would. So I can put a 0 here. Remember, that doesn't change the value of the number, or I can leave it off. It doesn't really matter. Either way, you're going to bring down a 2 here, and then just go to the left. 1 plus 4 is 5. 4 plus 0 is 4. 5 plus 9 is 14. So I put a 4 down and carry a 1. 1 plus 6 is 7. Plus 2 is 9. 3 plus 1 is 4. So we get 49.4452 as our answer. Let's just write this up here. 49.4452. All right, for the next one, we're going to add 3 numbers. So we have 13.0015 plus 17.201 plus 0.3958. So again, I'm just going to line them up by their decimal point. So 13.0015, 17.201, and 0.3958. And again, I can put a 0 here if I want, if it makes me feel more comfortable, or I can leave it off. It really doesn't matter. So I'll put my plus sign out here and bring my decimal down into the answer and just start adding. 5 plus 8 is 13. Put a 3 down and carry a 1. 1 plus 1 is 2, plus 1 is 3, plus 5 is 8. 0 plus 0 plus 9 is 9. 0 plus 2 plus 3 is 5. And let me move that decimal point up a little bit. 3 plus 7 is going to be 10, so I'll put a 0 down and carry a 1. And then 1 plus 1 plus 1 is going to be 3. So I end up with 30.5983. So let's put equals, and I'll put it over here, 30.5983. Hello and welcome to Pre-Algebra Test Section 2 on adding and subtracting decimals. So we want to perform each operation. We're going to start out with 20.683 minus 5.1000003. Again, if we're doing subtraction, the order is going to matter. So I'm going to put this guy on top, so 20.683, and this guy's going to go on the bottom, so 5.1000003. Put my subtraction sign, draw my little horizontal line, and I'm going to bring my decimal point down into the answer. And now I'm going to go and start subtracting. But what happens is if you're subtracting and your number on top has fewer digits out here, you just put some zeros in. Remember, that doesn't change the value of the number. And then we can go through and borrow. So I'm going to borrow from this 3. That's going to become 2. This will become 10, then 9, then this will become 10, then 9, and this will become 10. And we can start subtracting now in the right column. 10 minus 3 is 7. 9 minus 0 is 9. 9 minus 0 is 9. 2 minus 0 is 2. 8 minus 0 is 8. And 6 minus 1 is 5. And let me kind of clean this up a little bit. All right, now we're continuing. Next, we would have 0 minus 5. We need to borrow to do that, so this will become 1. This will become 10. 10 minus 5 is 5. And then I can just bring down the 1. So I end up with 15.582997. Let's write that up here. 15.582997. Okay, now we have 0.5 minus 0.413. So this has to go on top. So I'm going to put 0.5. This has to go on the bottom. So I'm putting 0.413. And again, I'm going to put some zeros after the 5. Doesn't change the value of the number. And we're going to start out by borrowing. So I borrow from the 5. This becomes a 4. This becomes a 10, then a 9, then a 10. So now I can subtract. 10 minus 3 is 7. 9 minus 1 is 8. 4 minus 4 is 0. And I made an error because I forgot to bring down my decimal point when I started. But again, as long as you do it before you finish the problem, you're okay. What happens is a lot of students will just forget about it and say, okay, the answer is 87. Boom. Again, it helps if you just make a habit of bringing it down before you start. Unfortunately, I didn't do that, but as long as you catch it before the end of the problem, you'll still get the right answer. So we'll put 0.087 as our final answer. Hello and welcome to Pre-Algebra Test Section 3 on adding and subtracting decimals. All right, we want to perform each operation, and we're going to start out here with a problem that has us adding 3 decimals. So we have 0.379 plus 52.8 plus 11.7216. All right, so we're just going to stack these numbers on top of each other, make sure to line them up by their decimal point. So I'm going to put 0.379 on top. We can put 52.8 kind of in the middle, and then 11.7216 on the bottom. Now for something like this, a lot of people will just put some zeros in. Remember, that doesn't change the value of the number. If you have a decimal point, after your last non-zero digit, you can put as many zeros as you want, right? It won't change the value of the number. So now we put our little addition sign out here, bring down my decimal point into the answer, and I start adding. 0 plus 0 plus 6 is 6. 9 plus 0 plus 1 is 10. I'm going to carry a 1. 1 plus 7 is 8, plus 0 is still 8, plus 2 is 10. Carry a 1. 1 plus 3 is 4, plus 8 is 12, plus 7 is 19. Put a 9 down, carry a 1. 1 plus 2 is 3, plus 1 is 4. And then 5 plus 1 is 6. So we're going to end up with 64.9006. And we can just write that up here. So we have 64.9006, again, as our answer. All right, next we have 0.24 minus 0.001 minus 0.08201. So I'm going to work left to right here. And because this is subtraction, the order does matter. So I'm going to have 0.24 on top minus, I'm going to have 0.001 on the bottom. Go ahead and bring down my decimal point to start. And I'm going to put a 0 right here so I can start subtracting. Borrow from the 4, this will become 3. This will become 10. And now I can do 10 minus 1, that's 9. 3 minus 0 is 3. 2 minus 0 is 2. So I end up with 0.239. And that's for this first part here. So 0.239. And now I'm going to subtract away 0.08201. So let's do that. So we have 0.239. That's got to go on top. And then 0.08201. That's got to go on the bottom. And again, I'm going to put some zeros up here. I'm going to borrow from the 9. That's going to become 8. This will become 10. Then 9. Then this will be 10. So then 10 minus 1 is 9. 9 minus 0 is still 9. 8 minus 2 is 6. I'll borrow again to do 3 minus 8. This will become 1. This will become 13. 13 minus 8 is 5. Then I have 1 minus 0, that's 1. And bring down the decimal point. Again, in a lot of videos, I forget to do that to start. But as long as you do it before you end the problem, you're okay. So I'm going to put that this is equal to 0.15699. Hello and welcome to Pre-Algebra Test Section 4 on adding and subtracting decimals. All right, we just want to perform each operation. So we have negative 6.051 plus negative 0.2753. All right, so just like when we were adding integers, basically if you have a negative plus a negative, you're going to get a negative. So it's the same thing when we're adding decimals. Now, once we've figured out what the sign is, we can just work with the absolute value. So we can just think about the numbers as if they were positive. So we would do 6.051 plus 0.2753. So I'm going to bring down my decimal point into the answer and then just start adding. So again, I can put a 0 here, or I can just bring down the 3. Either way, I'll have a 3 there to start. 1 plus 5 is 6. 5 plus 7 is 12. Put a 2 down, carry the 1. 1 plus 0 plus 2 is 3. And then bring down the 6. So we get 6.3263. Again, bring it back up here and stick it next to that negative. We'll have negative 6.3263. Okay, for the next one, we have negative 2.011 plus 5.37. So if we have a negative and a positive involved, just think about back when we were working with integers. We would first think about what the sign's going to be. So think about these numbers in terms of their absolute values. Think about these numbers as if they were both positive. 5.37 is bigger than if we had 2.011. Again, 2.011 is the absolute value of negative 2.011. So the sign's going to be positive. Now, once we figure that out, we just subtract the absolute values, right? We're going to do the larger absolute value minus the smaller. So we would do 5.37 minus 2.011. And to start, I need to put a 0 up here. And I'm going to borrow from the 7. The 7 will become a 6, and the 0 will become a 10. And now I can do 10 minus 1, that's 9. 6 minus 1, that's 5. 3 minus 0 is 3. And bring down the decimal point here. 5 minus 2 is 3. So we're going to get a positive 3.359 as our answer. Hello and welcome to Pre-Algebra Test Section 5 on adding and subtracting decimals. All right, so we just want to perform each operation. And what we're looking at here is one problem where we have 14 plus, we have negative 7.1 plus negative 0.6305 minus a negative 4.103. So the first thing I'm going to do is just rewrite this, and I'm going to rewrite it with 14 plus we have negative 7.1 plus we have negative 0.6305 minus a negative is plus a positive. So I'm going to put plus positive 4.103. Now what I'm going to do is reorder it one more time to where my positive numbers are next to each other and my negative numbers are next to each other. So I'm going to have 14 plus 4.103 plus negative 7.1 plus negative 0.6305. So to make it easy on myself, I'm going to add the positive numbers together first. Then I'm going to add the negative numbers together, and then I'll do one final mixed addition. So if we do 14 plus 4.103, I don't see a decimal point in 14, but when I have a whole number, I can put a decimal point after the final digit, and then I can put some zeros after it if I want. So let's put 2 zeros after it or 3 zeros after it. And then I have 4.103. So we'll just add there. 0 plus 3 is 3. 0 plus 0 is 0. 0 plus 1 is 1. Bring down that decimal point. 4 plus 4 is 8. And bring down the 1. So I get 18.103. So then plus, we're looking for the result of this guy right here. I know that it's going to be negative because I have negative plus another negative. That results in a negative. So you just add these over to the side using their absolute values. So 7.1 plus, we'll have 0.6305. And I'll bring down the 5, the 0, the 3. 1 plus 6 is 7. Bring down my decimal point and then bring down the 7. So this will be negative 7.7305. All right, so my last part is going to be a mixed addition. I have a positive plus a negative. So when this occurs, again, I always want to think about what the sign of the answer is going to be first. Clearly, 18.103 is bigger in terms of its absolute value than if we're looking at the absolute value of negative 7.7305. So the sign of the answer will be positive. Now I just want to subtract. Remember, I do the larger absolute value minus the smaller. So we do 18.103 minus 7.7305. And I'm going to put this decimal point down here so that I don't forget about it later. And I'm going to put a 0 out here. And I'm going to start my subtraction. I'm going to borrow here. This will become 2. This will become 10. 10 minus 5 is 5. 2 minus 0 is 2. I'm going to borrow again. This will become 0. This will become 10. 10 minus 3 is 7. Need to borrow one more time. This will become 7. This will become 10. 10 minus 7 is 3. I already have my decimal point down. 7 minus 7 is 0. Bring down the 1. So I get 10.3725. So I bring that back up here as 10.3725. That's my final answer. Hello and welcome to Pre-Algebra Practice Set number 42. In this video, we're going to look at some additional practice problems for our lesson on multiplying decimals. All right, so we just want to find each product. And for our first problem, we have 0.1801 times 3.2. So basically, the way you attack these problems, you ignore the decimal points that you have, and you pretend that you have whole numbers. So for example, with this number, I'm going to pretend like I have the number 1,801. With this number, I'm going to pretend like I have the number 32. Now, once we find this product here, we're going to go back and figure out where to put our decimal point. So we have 2 times 1, that's 2. 2 times 0 is 0. 2 times 8 is 16. Place a 6 down, carry a 1. 2 times 1 is 2, plus 1 is 3. Now, I'm moving to the 3 here, so I got to start my answer one place to the left. And let's begin. 3 times 1 is 3. 3 times 0 is 0. 3 times 8 is 24. Put a 4 down, carry the 2. And then 3 times 1 is 3, plus 2 is 5. All right, so now we're going to add. Bring down the 2. 0 plus 3 is 3. 6 plus 0 is 6. 3 plus 4 is 7. And let me make that a little bit better. Again, 3 plus 4 is 7. And then bring down the 5. So what I get is 57,632. But of course, this is not our answer, right? Let's just write this up here. 57,632. We can go ahead and erase this. We don't need it anymore. Now, obviously, this is not our answer because this is a whole number, and we know that when we multiply these two together, we're going to get some kind of decimal point involved somewhere other than all the way to the right like we'd have with a whole number. So how do we figure out where the decimal point's going to go? Well, basically what we do is we count the total number of decimal places between all the factors involved in the multiplication problem. So in this problem, we have 2 factors. So we would count 1, 2, 3, 4, and then a 5th one over here. So 4 decimal places here, and then 1 over here to make a total of 5 decimal places between all the factors. Now, we're going to move our decimal point one place to the left for every decimal place that we have between these factors. So the decimal point in a whole number is always at the very end of a number. So it's right there now, and I'm just going to move it 5 places to the left. So 1, 2, 3, 4, and then finally 5. And I'll put my decimal point there. And of course, you can put a 0 out here in front if you want, just for clarity. So we can say our answer here is 0.57632. All right, let's take a look at another one. We have 13.21 times a negative 5.29. So we have a positive times a negative. Let's just put a negative out here to start. And now we could just think about the numbers in terms of their absolute values. Or again, we could just think about them as if they were all positive. So again, when you're multiplying with decimals, just ignore the decimal points to start. So I'm going to pretend like I have 1,321 times 529. And again, I ignored the negative here because I already calculated the sign. So let's begin this part. We have 9 times 1, that's 9. Then 9 times 2 is 18. 8 down, carry the 1. 9 times 3 is 27, plus 1 is 28. 8 down, carry the 2. 9 times 1 is 9, plus 2 is 11. All right, so we're moving to the 2. That's in the tens place, so I'm going to move over 1 place to the left when I start my answer. 2 times 1 is 2. 2 times 2 is 4. 2 times 3 is 6. Then 2 times 1 is 2. Okay, and then I'm going to the hundreds place. So I'm going to start my answer 1 more place to the left. 5 times 1 is 5. 5 times 2 is 10. 0 down, carry the 1. 5 times 3 is 15, plus 1 is 16. 6 down, carry the 1. 5 times 1 is 5, plus 1 is 6. All right, so let's add now. We're going to bring down that 9. 8 plus 2 is 10. Put a 0 down, carry the 1. 1 plus 8 is 9, plus 4 is 13, plus 5 is 18. 8 down, carry the 1. 1 plus 1 is 2, plus 6 is 8, plus 0 is still 8. Then we'd have 1 plus 2, which is 3, plus 6, which is 9, and then bring down the 6. So I have 698,809. So I'm just going to copy this and bring it up to the top. All right, we put that next to the negative. And now we just need to figure out where our decimal point is going to go. So again, I'm going to look at how many decimal places I have between all the factors. So I have 1, 2 decimal places here, and then 1, 2 decimal places here. 2 plus 2 would give me 4. So that means I'm going to move the decimal point 4 places to the left. Again, when you start out with this whole number here, the decimal point's all the way to the right. So it's going to go 1, 2, 3, 4 places to the left. And so my decimal point will be after that 9 there. And that will give me a final answer of negative 69.8809. All right, let's take a look at a problem with 3 numbers involved. And there's a few different ways you can do this. The first thing I'm going to do when I look at this, notice that we have negative 4.1 times negative 6.23 times 1.5. Between all the factors, I have 2 negatives. 2 is an even number, so I know that the final answer here is going to be positive. No matter how I do it, it's going to be positive. So now I can just think about the numbers in terms of their absolute values. Now what I'd like to do is just multiply these 2 numbers together to start. And so again, I'm going to pretend they're both positive, and I'm going to ignore the decimal points. So I'm going to pretend that I have 623 times 41. 1 times 623 is 623. And then I'm moving to the left because I'm starting in the tens place. 4 times 3 is 12. I'm going to put a 2 down, carry a 1. 4 times 2 is 8, plus 1 is 9. 4 times 6 is going to be 24. All right, let's add. Bring down the 3. 2 plus 2 is 4. 6 plus 9 is 15. Put the 5 down, carry the 1. 1 plus 4 is 5. Bring down the 2. So I'm going to get 25,543. Now, you can go through and figure out where your decimal point is going to be and have that number and then multiply it by this one. But what makes more sense is just to figure out where the decimal point is going to be in the very, very end. So in other words, I'm going to take this result here, this 25,543, and I'm going to multiply it by 15. I'm going to pretend that that decimal point is not there. So 25,543 times 15. When we're done, once we have an answer here, we'll go back and figure out where the decimal point is going to be by just counting the number of decimal places we have between all factors and moving our decimal point to the left by that number of places. So we begin with 5 times 3, that's 15. Put a 5 down, carry the 1. 5 times 4 is 20, plus 1 is 21. 1 down, carry the 2. 5 times 5 is 25, plus 2 is 27. 7 down, carry the 2. 5 times 5 is 25, plus 2 is 27. 7 down, carry the 2. Then 5 times 2 is 10, plus 2 is 12. All right, now we're moving 1 place to the left because we're starting in the tens place here. But notice that we have a 1. So 1 times anything is itself. So I can just pretty much copy this number. 3, 4, 5, 5, 2. Right? 1 times 25,543 is 25,543. So we're going to add, bring down that 5. 1 plus 3 is 4. 7 plus 4 is 11. 1 down, carry a 1. 1 plus 7 is 8, plus 5 is 13. 3 down, carry a 1. 1 plus 2 is 3, plus 5 is 8. And then 1 plus 2 is 3. So that gives me 383,145. So let's write that over here. 383,145. And let me erase that comma. All right, so let's get rid of all this now. Our final step is just going to be where do we put our decimal point? Because it's not going to be over here like it is now. Well, if we look between the factors, I have 1 decimal place here. I have 2 decimal places here. And I have 1 decimal place here. So I just add. 1 plus 2 is 3. 3 plus 1 is 4. So that tells me I need to move that decimal point 4 places to the left. So this goes 1, 2, 3, 4 places to the left. And so it's going to go right after that 8 there. And we'd end up with 38 point, let me kind of move this over a little bit, 38.3145. All right, let's take a look at a few problems that deal with multiplying by 10 or a power of 10. So before we kind of get into this, let me just cover this in case you didn't watch the lesson. If you multiply by 10 or a power of 10, and when I say power of 10, specifically I mean 10 raised to a whole number that is 1 or larger. meaning let's say you have 10 to the power of 1 or 10 to the power of 2 or 10 to the power of 3, so on and so forth. I'm not talking about 10 raised to the power of 0 or 10 raised to some, negative power, like 10 raised to the power negative 4, for example. So just these values here that follow this pattern. When you work with this, basically you can move your decimal point one place to the right for every 0 in the power of 10 you're multiplying by. So I know that 1,000 is 10 to the third power. And how do I know that? Let's kind of backtrack a little bit on that too. We had a lesson where we talked about if we had 10 as a base and we had an exponent that was a whole number that was 1 or larger, we could figure out the value for this by writing a 1 followed by the exponent number of zeros. So in this case, 10 to the fourth is a 1 followed by 4 zeros. 1, 2, 3, 4. 10 cubed is a 1 followed by 3 zeros. 1, 2, 3. 10 to, let's say, the 7th power is a 1 followed by 7 zeros. 1, 2, 3, 4, 5, 6, 7. And let me put some commas in here. And I should put a comma in there too. So in any case, we can kind of use a shortcut. In this case, we can just look at the fact that it's 1,000 and see, okay, we have 3 zeros here. If I'm going to multiply 3.675 times 1,000, all I really need to do is take that number 3.675 and move the decimal point 1, 2, 3 places to the right, and I'll end up with my answer of 3,675. If I saw it in this format, 3.675 times 10 cubed, which 10 cubed is the same thing as 1,000, I can kind of use a double shortcut. I don't need to evaluate 10 cubed because I know that 10 cubed is a power of 10 that contains a 1 followed by 3 zeros, right? The exponent is a 3. So all I need to do is look at that exponent there to tell me how many places I'd move my decimal point over, right? I would take 3.675, and again, 3 is the exponent on 10, so this goes 1, 2, 3 places to the right, and again, I get 3,675. Let's look at another one. So we have 0.00159 times 10 to the 6th power. So again, very, very easy to crank this out. So if I'm multiplying by 10 raised to the 6th power, the exponent on 10 is a 6. That tells me that I'm going to have 6 zeros, right? I'd have a 1 followed by 6 zeros if I were to evaluate that. So I just need to move this decimal point 1, 2, 3, 4, 5, 6 places to the right. And I can erase these zeros here. They're not going to add any value to that number. I'm going to end up with the number 1,590. For the last one, we have 0.21 times 10 to the 4th power. So again, the exponent on 10 is a 4. So that just tells me to take this number 0.21 and move my decimal point 1, 2, 3, and finally 4 places to the right. So I'm going to end up with the number 2,100 as my answer. Hello and welcome to Pre-Algebra Test Section 1 on multiplying decimals. All right, so we just want to find each product. And we're going to begin today with 0.305 times 2.6. So the first thing we want to do when we're multiplying with decimals is we want to ignore any decimal points that we come across, and we want to just multiply like if we had some whole numbers. So I'm going to think about this number as 305, and I'm going to think about this number as just 26. So we'll perform this multiplication first, and then once we have the answer, I'll show you how to find the correct place to put the decimal point. So we begin. 6 times 5 is 30. 0 down, carry the 3. 6 times 0 is 0, plus 3 is 3. 6 times 3 is 18. So remember now, because I'm starting in the tens place here, I'm going to start my answer off one place to the left. And 2 times 5 is going to give me 10. Put a 0 down, carry the 1. 2 times 0 is 0, plus 1 is 1. And then 2 times 3 is 6. So now we're going to add. And let me scroll down a little bit. So I can just bring down that 0. 3 plus 0 is 3. 8 plus 1 is 9. And 1 plus 6 is 7. So I get 7,930. But of course, that's not my answer. I have to figure out where to put the decimal point at. So let me take this and just drag it up to the top. So I'm going to put that this equals 7,930. Now, the way that you figure out where to put the decimal point is you count the total number of decimal places, meaning the places to the right of the decimal point between all of the factors. So if I look at these two factors here, I have 1, 2, 3 decimal places here, and I have 1 decimal place here. So 3 plus 1 is 4. So essentially, for any whole number, the decimal point is at the very end of it. So I'd place it there, and I would just move it 4 places to the left. So I would go 1, 2, 3, 4 places to the left. And so our final answer here is going to be 0.793. And remember, I can get rid of that 0 because it does not add any value to the number, right? 0.793 is the same as 0.793. All right, so for the next problem, we have negative 1.25 times 10 squared. So this problem kind of relates to that section in the lesson where we talked about multiplying by 10 or a power of 10. So here's the rule. If you multiply by 10 or a power of 10, and let me be specific real quick. When I say power of 10, I mean 10 raised to a whole number that's 1 or larger. What we do is we move our decimal point 1 place to the right for every 0 in the power of 10. And another thing I want you to remember, if we have 10 as a base and we have a whole number exponent that's 1 or larger, to evaluate, basically we write a 1 followed by the exponent number of zeros. So in the example of 10 squared, I basically would write a 1 followed by 2 zeros. So 10 squared is 100. If I had, let's say, 10 to the 5th power, I would write a 1 followed by 5 zeros. 1, 2, 3, 4, 5. So that's 100,000. So if we see a number in exponent form like this, where the base is 10 and the exponent is a whole number that's 1 or larger, we can basically use a double shortcut. We don't need to even evaluate this and find out that it's 100. We can just say that the exponent on 10 is a 2, so I know I'll have 2 zeros there, and therefore I would just move the decimal point in this number 2 places to the right. So this would be equal to, we have that number negative 1.25, and again, I would just move the decimal point 2 places to the right because the exponent on 10 is a 2, right? So I'm going to end up with, as an answer, negative 125. Hello and welcome to Pre-Algebra Test Section 2 on multiplying decimals. All right, so we just want to find each product, and we're going to start out with multiplying 3 numbers here. So the first thing I'm going to think about is, what's the sign of this product going to be? I have negative 0.485 times negative 0.13 times negative 3.9. So negative times negative times negative is negative, right? I have an odd number of negatives involved. That's going to give me a negative result. So now I can just pretend the numbers are positive. And another thing I can do is just pretend that I don't have any decimal points at all. So I'm going to think about, what is 485 times 13 times 39? Well, let's do this multiplication first. 485 times 13. 3 times 5 is 15. 3 times 8 is 24, plus 1 is 25. 3 times 4 is 12, plus 2 is 14. Next, I'm going to have 1 times 485. That's 485. Again, just make sure you move this over to the left. Now we add, bring down the 5. 5 plus 5 is 10. 1 plus 4 is 5, plus 8 is 13. 1 plus 1 is 2, plus 4 is 6. So I've got 6,305. So I'm going to replace this with 6,305. Again, and we're multiplying by 39 now. So 6,305 times 39. 9 times 5 is 45. 9 times 0 is 0, plus 4 is 4. 9 times 3 is 27. 9 times 6 is 54, plus 2 is 56. All right, move over to the left. 3 times 5 is 15. 3 times 0 is 0, plus 1 is 1. 3 times 3 is 9. Then 3 times 6 is 18. So now all I have to do is add, bring down the 5. 4 plus 5 is 9. 7 plus 1 is 8. 6 plus 9 is 15. So I'm going to put a 5 down, carry a 1. 1 plus 5 is 6. 6 plus 8 is 14. Put a 4 down, carry a 1. 1 plus 1 is 2. So I've got 245,895. Let me kind of erase this real quick. Again, I know that it's negative, And the result I found was 245,895. Now let's get rid of this comma for a minute. What we're going to do now is figure out where to put our decimal point. So what we're going to do is count the number of decimal places between all the factors. So we've got 1, 2, 3 here, 1, 2 here, and 1 here. So that's a total of 6, right? 6 decimal places. So once we count this number, we basically just move our decimal point that many places to the left. So remember, if you have something like this, you can put a decimal point at the end, and then we're going 1, 2, 3, 4, 5, 6 places to the left. So we'd end up with negative 0.245895. Hello and welcome to Pre-Algebra Test Section 3 on multiplying decimals. All right, so we just want to find each product, and we're going to begin with negative 51 times 0.0005. So the first thing that we should notice is that we have a negative times a positive. So negative times positive gives us a negative. And I like to get that out of the way first so that I can work with the absolute values, right? I can just think about everything as if it was positive. Now the next thing is when we're multiplying with decimals, we're going to begin the problem by ignoring any decimal points we come across. So I would just think about the problem 51 times 5. Right? If I don't think about this decimal point here, then I'd have a bunch of zeros in front of a 5. Really wouldn't add any value, so I would just have the number 5. So what is 51 times 5? 5 times 1 is 5. 5 times 5 is 25. So I can drag this up here. And of course, this isn't our answer. The next step is just to figure out where we're going to put our decimal point in this number right here. Well, what we do is we look at how many decimal places, meaning places to the right of the decimal point, we have between the two factors. Well, I'm not going to have any here, and here I'm going to have 1, 2, 3, 4 of them. So essentially, for every decimal place I have between the factors, I move my decimal point one place to the left. So in a whole number, you put your decimal point at the very end or to the very right. And so I would go 1, 2, 3. I need to put in a 0, 4 places to the left, and I'd end up with negative 0.0255 as my answer. Okay, for the next problem, we have 3.2 times negative 6.1 times 100. So what we're going to do here is we're going to find the product here first, and then we'll multiply by 100 using our little trick. So the first thing I would notice is that we have a positive times a negative. That's going to give me a negative. And even when we multiply by 100, that's times another positive. So the net result for this whole problem is that I have an odd number of negative factors, and so I'm going to have a negative result. So now I can just think about everything as if it's positive, right, in terms of absolute value. When I think about doing 3.2 times 6.1, again, I'm not worried about the negative because I already know the sign. So when I think about doing 3.2 times 6.1, I ignore the decimal points and I do 32 times 61. 1 times 32 is 32. Then 6 times 2 is 12. 2 down, carry the 1. 6 times 3 is 18, plus 1 is 19. And we're going to add. Let me kind of straighten that out a little bit. Bring down the 2. 3 plus 2 is 5. Bring down the 9. Bring down the 1. So 1,952. So the question is, where's the decimal point going to be for that number? Let me erase this. So 1,952. So when we multiply these two numbers together, essentially once we have this answer, we count the number of decimal places between the factors. In this case, we have 2, right? 1 right there and 1 right there. And for each decimal place we have, we move our decimal point one place to the left. So this one ended up going 1, 2 places to the left. And of course it would be negative, but it would be negative 19.52, right? And the reason I'm not writing a negative out in front is we have one more step to go. So we can just kind of still think about this in terms of being positive. Now, the last thing we're going to do is multiply by 100. And essentially it's just going to reverse what we did. And what do I mean by that? Well, when you multiply by 10 or a power of 10, you're going to move your decimal point one place to the right for every 0 in the power of 10. So there's 2 zeros here. So now I'm going to go 2 places to the right. Right? Remember, we went 2 places to the left. Now we're going 2 places to the right. Essentially, I just reversed what I just did. So what I'm going to end up with is 1,952. Of course, I need to attach that to the negative to give me a final answer for this problem of negative 1,952. Hello and welcome to Pre-Algebra Test Section 4 on multiplying decimals. All right, so we just want to find each product, and we're going to begin with 0.198652015 times 10 to the 7th power. So this is a very, very easy problem. Essentially, what we're doing here is we're saying that when we multiply by 10 or a power of 10, so in this case I have 10 raised to the power of 7, I'm going to move my decimal point one place to the right for every 0 in the power of 10. Now, one thing I taught you is that when you're working with exponents and you have a base of 10, you've got a whole number exponent that's 1 or larger, you can tell how many zeros you're going to have just by looking at the exponent, right? So 10 to the 7th is a 1 followed by the exponent number of zeros. So 7 zeros. 1, 2, 3, 4, 5, 6, 7. Right? So this is going to give me the number 10 million. So essentially, I don't even need to go through and do that, though. Once I notice that the exponent is 7, to get the answer for this problem, let's just write this leftmost number here, 0.198652015. All I need to do is move my decimal point 7 places to the right because the exponent on 10 is a 7. So I'm going to go 1, 2, 3, 4, 5, 6, and finally 7. So my decimal point would go right there. And I'm going to put some commas in here, one there and then one there, to give me the number 1,986,520.15 as my answer. All right, similarly, we have 83.22 times 10,000. So I can count the number of zeros here. I have 1, 2, 3, 4. If I had written this in the same format as the other problem, I would have just written times 10 to the 4th power. Either way, whether you have a 4 as your exponent for 10, or whether you write it as 10,000 where you have basically 4 zeros that you're able to just straight up count, you know that you're going to move your decimal point 4 places to the right. So I'm going to take my 83.22 and I'm going to put 2 zeros behind that final 2. And then I'm going to move this decimal point 1, 2, 3, 4 places to the right. And I'll put in a comma here. This is going to give me a final answer of 832,200. Hello and welcome to Pre-Algebra Test Section 5 on multiplying decimals. Okay, so we just want to find each product. And we only have one problem here, but it's kind of a tedious one. And there's some things that are going to help us out here. So let me read this. We have negative 2.27 times negative 4.5 times negative 10,000 times negative 1.64. Well, the first thing is, let's figure out our sign. We have 4 negatives involved. 4 is an even number, so we know the answer is going to be positive. So now I can just think about all these numbers as if they were positive. I don't need to worry about the sign anymore. The next thing is, when I look at this factor here, I know it's negative 10,000, but again, we're going to just think about it as if it's 10,000 because we already know the sign. When I multiply by 10, or again, a power of 10, meaning I multiply by 10 raised to a whole number that's 1 or larger, I move my decimal point one place to the right for each 0 in that power of 10. So knowing that, I'm going to save this until last. I'm not going to worry about that factor. So I'm just going to think about 2.27, 4.5, and 1.64. And again, I didn't write any of them as negative because I already know my sign. So to multiply these to start, forget about the decimal points. So I'd have 227 times 45. 5 times 7 is 35. 5 times 2 is 10, plus 3 is 13. 5 times 2 is 10, plus 1 is 11. So now I'm doing 4 times 7, that's 28. 4 times 2 is 8, plus 2 is 10. 4 times 2 is 8, plus 1 is 9. So if we add here, bring down the 5, 3 plus 8 is 11. 1 plus 1 is 2, plus 0 is still 2. Then 1 plus 9 is 10. So 10,215. 10,215. So let me just write this as 10,215 like that. And let's go ahead and figure out where our decimal point is going to be. Again, what we do is look for how many decimal places we have between the factors. I just multiplied these numbers together. So I have 1, 2, 3 decimal places between the factors. So my decimal point would go 3 places to the left. So it would be right there. Right? So I'd have 10.215. All right, so let's rewrite this as 10.215 times 1.64. So now we're going to perform this operation. And again, I'm going to ignore my decimal points. So I'd have 10,215 times 164. 4 times 5 is 20. And let me scroll all the way down because we need a little room for this. 4 times 1 is 4, plus 2 is 6. 4 times 2 is 8. 4 times 0 is 0. 4 times 1 is 4. Now we're moving to the left. We have 6 times 5, that's 30. 6 times 1 is 6, plus 3 is 9. 6 times 2 is 12. 6 times 0 is 0, plus 1 is 1. 6 times 1 is 6. Then lastly, I have 1 times 10,215. But again, you got to scoot this over to start. So 5, 1, 2, 0, 1. And let me kind of move this over so I can fit it on my screen. There we go. So now I'm going to add this. Bring down the 0. 6 plus 0 is 6. 8 plus 9 is 17. 17 plus 5 is 22. 2 plus 0 is 2. Plus 2 is 4. Plus 1 is 5. 4 plus 1 is 5. Plus 2 is 7. 6 plus 0 is 6. Bring down the 1. So I get 1,675,260. Let's put equals 1,675,260. Now where's my decimal point going to go? Well, I have 1, 2, 3, 4, 5 decimal places between these two factors. So my decimal point is going to go 1, 2, 3, 4, 5 places to the left. And we end up with 16.7526. I can cut that 0 off because once I have my decimal point, after my final non-zero digit, the zeros after it won't matter, right? I can put as many zeros after that 6 as I want. Will not change the value of the number. So let's take this 16.7526 and bring it up to the top. Okay, so we've got 16.7526. Now the final thing I'm doing is I'm multiplying by 10,000. Again, we already figured out our signs. Everything now we're just treating it as if it was positive. So when I multiply by 10,000, again, the trick is I have 1, 2, 3, 4 zeros there. So my decimal point is going to go 1, 2, 3, 4 places to the right. So I can just kind of erase that and just leave the number like this, put a little comma in there, and I get a final answer of 167,526. Hello and welcome to Pre-Algebra Practice Set number 43. In this video, we're going to look at some additional practice problems for our lesson on dividing decimals. All right, so we just want to find each quotient, and we're going to start out with a pretty easy one. We have 1.26 divided by 6. So when we take a decimal and we divide by a whole number, we basically just have one additional step. So when we set up our long division, we just do it normally. So I'm going to put my dividend 1.26 underneath, and to the left, I'm going to put my divisor 6. Now here comes the additional step. You're just going to take that decimal point and bring it up into the answer, put it up there, and then you're done with it. Now I can divide as if I had 126 divided by 6, right? I don't need to think about the decimal point anymore. So I'll start out with, does 6 go into 1? No. Does 6 go into 12? Yes, it does. 2 times. So put a 2 here. 2 times 6 is 12. Subtract and I'll get 0. Bring down the 6. 6 is going to go into 6 once. 1 times 6 is 6. Subtract and get 0. So my answer for this problem is going to be 0.21, or I like to write 0.21, just to get a little clarity going. And the great thing about division, as I've talked about in other videos, is that you can always check it with multiplication. So what we're going to do here, we're going to take our quotient, which is 0.21, and we're going to multiply it by the divisor. So we're going to go this way. So 0.21 times 6 should give me 1.26 back, right, my dividend. So 21 times 6. 6 times 1 is 6. 6 times 2 is 12. So I get 126. And then between these two factors, I'd have 2 decimal places. So that decimal point would go 2 places to the left. And yeah, I'd end up with 1.26 as my answer, right? And that's exactly what I have as my dividend when I started. So now we can confirm the fact that 1.26 divided by 6 is 0.21. All right, let's take a look at another easy one. We have 13.9 divided by 3. So 13.9 divided by 3. Again, just set the long division up normally. The only additional step you have is to take that decimal point, bring it up into the answer. Once you've done that, you can forget about it. You can pretend like you have 139 divided by 3. So 3 is not going to go into 1. It will go into 13 4 times. 4 times 3 is 12. If we subtract here, we'll get 1. And we'll bring down the 9. 3 is going to go into 19 6 times. 6 times 3 is 18. If we subtract here, we'll get 1. So remember, we're allowed to continue our division now. We learned in the lesson that we don't have to stop when we don't have anything else to bring down, because after a decimal point and you have your final non-zero digit, you can put as many zeros after as you want, and you won't change the value of the number. So for example, here after this 9, I can put a 0, and it's still 13.9, right? It still has the same value. And then I can bring this down so I can continue my division. So 3 is going to go into 10 3 times. 3 times 3 is 9. Subtract, and we would get 1. I can put another 0 so I can continue the division. Bringing this down, and you'd have 10 again. 3 goes into 10, again, 3 times. 3 times 3 is 9. Subtract, and you get 1. So I'm going to stop here because most of you will notice that you have something called a repeating pattern. So what happens is on some of these division problems, you're going to get the same digit or the same series of digits that repeat forever. I'm going to keep multiplying 3 by 3 and getting 9. I'm going to keep subtracting it away from 10 and getting a result of 1. I'm going to keep bringing down a 0 and getting another 10. This pattern is going to continue forever and ever and ever. I'll keep getting 3s. So what we're going to do, let's just erase everything, and we'll write our answer using this notation. We're going to write 4.63. Now 3 is the digit that repeats forever, so we're going to put a little bar, a horizontal bar on top of that number. When we come to the situation where we have a series of digits that repeat, we just need to make sure we put the bar over every digit in that series. So our answer here is going to be 4.63, again with a horizontal bar over the 3 to tell us that that number is going to repeat forever. Okay, for the next problem, we have 18,791 divided by 10,000. So a very, very simple problem. Essentially, we're just practicing dividing by 10 or a power of 10. So if you divide by 10 or a power of 10, and when I say power of 10, I mean 10 raised to a power that's a whole number that's 1 or larger, you basically move your decimal point 1 place to the left for every 0 in the power of 10. And then earlier we learned that if we had something in exponent form and the base was 10 and the exponent was a whole number of 1 or larger, let's say it's 4 for example, I can evaluate it by writing a 1 followed by the exponent number of zeros. So 4 zeros. 1, 2, 3, 4. So 10,000. That's what we have here. So if you were to see this problem written as 18,791 divided by 10 to the 4th, you know that you're going to have 4 zeros in that power of 10. So your decimal point goes 4 places to the left. If you were to see it written as it is here, you can just go through and count the zeros. You have 1, 2, 3, 4. And essentially, again, you're just going to move the decimal point 4 places to the left. So you have 18,791. For a whole number, the decimal point is all the way to the right. And we begin. We go 1, 2, 3, 4 places to the left. And we would end up with the number 1.8791. All right, let's take a look at another one. We have negative 1.728 divided by 9. So the first thing is, if you see a negative in any part of your problem, just figure out what the sign is going to be so that you can think about the numbers in terms of their absolute values, right? You could just pretend everything is positive at that point. So negative divided by positive is a negative. And now I can just think about, well, what's the problem? 1.728 divided by 9, right? Set it up this way. bring your decimal point up into the answer, and then just start your division. 9 will not go into 1, but it will go into 17. It'll go in only once. 1 times 9 is 9. If we subtract here, 17 minus 9 is going to give me 8. Bring down that 2. I know that 9 will go into 82 9 times. 9 times 9 is 81. Subtract and get 1. Go ahead and bring down that 8 there. And 9 goes into 18 exactly twice. 2 times 9 is 18. Subtract and get 0. So we're going to end up with 0.192. But remember, we said that the answer was negative. So I'm going to write negative 0.192 as my final answer. All right, let's take a look at one where we're dividing by a decimal. So we have 59 divided by 2.4. So when you come across this scenario, what you need to do is move your decimal point in your divisor. Remember, that's what you're dividing by. This is called a divisor, and this is called a dividend. Move the decimal point in the divisor enough places to the right to make it a whole number. So in this case, I just need to move it one place to the right. Now, it's not legal unless you do it to the dividend as well. So I need to take this decimal point, which is after the 9. I'm going to put a 0 in there and just bring that one place to the right as well. Essentially, you're just multiplying both of them by 10, right? If I had 59 over 2.4 written like this using a fraction, just think about multiplying by 10 over 10. Right? I'm multiplying by a complex form of 1. 59 times 10 is 590. And this is over 2.4 times 10, which is 24. Right? Just moving the decimal point one place to the right. So let's write this division problem again as 590 divided by 24. Okay, so let's set this up using long division format. So 24 is not going to go into 5. It will go into 59 twice. 2 times 24 is 48. We're going to subtract here. 9 minus 8 is 1. 5 minus 4 is 1. So I have 11, and I'm going to bring down this 0. So how many times will 24 go into 110? Well, I know that 24 times 5 is 120. That's too big, so it's going to have to be one less than that. We're going to have to use 4. So 4 times 24, let's think about 4 times 20, that's 80. 4 times 4 is 16. 80 plus 16 is 96. So I'm going to put 96 here, and we're going to subtract. And I would need to borrow. 10 minus 6 is 4. Borrow again. 10 minus 9 is 1. So I'd have 14 as a remainder. Now, we're going to continue the division by putting a decimal point here. Bring that up into the answer. And we're going to put a 0 behind that decimal point and bring that down so that we can continue the division. Now, 24 goes into 140 how many times? Well, I know that 24 times 5 is 120. If I take 120 and I add 24 more to it, I'm going to get 144. That's too big. That's bigger than 140. So I'm going to have to go with 5. As I just said, 5 times 24 is 120. So you're going to write that underneath, and you're going to subtract. So 0 minus 0 is 0. 4 minus 2 is 2. 1 minus 1 is 0. So we're going to continue by just putting another 0 there and bringing that guy down. So how many times will 24 go into 200? Well, kind of a mental way to do this, 24 times 10 is 240. That's too big, obviously. If I took 24 away from it, right, meaning if I did 24 times 9, but I'm just kind of doing this using subtraction. If I start with 240, and let's say I mentally subtract 24 away, I can look at that and know that I'm not going to be at or below 200. So it can't be 9. It has to be 8, right? It has to be 8. So let's put an 8 as our answer. 8 times 24. 24 times 8. 8 times 4 is 32. 2 down, carry the 3. 8 times 2 is 16. Plus 3 is 19. So you'll have 192. So let's subtract 192. And 200 minus 192 is going to give me 8. All right, let's go up here. Put a 0 and bring that guy down. So now how many times will 24 go into 80? And I know 24 is cut off at the top of the screen there, but most of you will know that 24 times 3 is 72. So that's as close as we can get without going over. So put a 3 here. 3 times 24, as I just said, is 72. Subtract here, and you're going to get 8. Now, I had 8 here. I brought down a 0. I had 80. It went in only 3 times. 3 times 24 gave me 72. I got 8 again. this is going to be an infinitely repeating pattern, right? If I bring down a 0, what's going to happen is, again, 24 goes into 80 3 times. So I'll have another 3 here. 3 times 24 is 72. 72, we subtract it away, we're going to get 8 again. This is going to continue forever and ever and ever. So we can stop at this point once we figure that out. So we'll go back up to the top, and we're just going to write as our answer, I'll put equals over here, 24.583. And on top of the 3, I'm going to put a horizontal line or a horizontal bar. That bar is telling me that that 3 is going to repeat forever and ever and ever, right? There's not going to be an end to it. Okay, let's take a look at 15.9 divided by 3.2. So again, if I am dividing by a decimal, I need to move the decimal point over in the divisor by enough places to make it into a whole number. The catch is I also have to do that to the dividend. So if I move this one place to the right, I have to move this one place to the right, and I'm going to end up with the problem 159 divided by 32. So let's go ahead and set that up using a long division. So 32 is going to go into 159 how many times? So 32 will not go into 1, will not go into 15. It will go into 159, but think about this. 30 times 5 is 150. Okay, so that's kind of this part of the number. If you think about this part of the number, though, 2 times 5 is 10. If I added 150 and 10 together, I would get 160. That's one larger than this, so that's too big. So I have to go with 4. So 4 times 32. 4 times 30 is 120. 4 times 2 is 8, so this would be 128. Subtract here. 9 minus 8 is 1. 5 minus 2 is 3. So I've got 31 as a remainder. And you can see that we got the right answer because this is smaller than this, right? So now I'm going to put a decimal point here, bring it up into the answer, put a 0, and bring that guy down. So how many times will 32 go into 310? Well, that's kind of an easy one because 32 times 10 is 320. That's too big. So I can go 1 down from that and go to 9, and that should work out. So I'm going to put a 9 here, and 9 times 32. 9 times 30, you do 9 times 3, that's 27. Put a 0 at the end, it's 270. Then 9 times 2 is 18. So 270 plus 18 is going to be 288. All right, so now we're going to subtract. I'll borrow here. This will become 10. 10 minus 8 is 2. Borrow again. This will become 2. This will become 10. 10 minus 8 is 2. So I've got 22 now. Put another 0. Bring that guy down. So how many times will 32 go into 220? So how do we make a guess on that? Well, again, I know 32 times 10 is 320. 32 times 10 is 320. If I mentally cut that in half, it's 160. So 32 times 5 is 160. If I did 32 times 6, I can mentally just add 160 and 32 and get 192. That's as close as I can get without going over here. If I add 32 to 192, just think about adding 2 first, right? You get to 194. And then if I add 30 to that, it's going to be 224. It's bigger than this. So we're going to have to go with a 6. Again, 6 times 32 is 192. And so let's subtract now. So 220 minus 192. Borrow from this 2, this will be 1. This will be 10. 10 minus 2 is 8. Borrow from this 2, this will be 1. This will be 11. 11 minus 9 is 2. So I'd have 28. So let's go up to the top, put another 0, and we'll bring this all the way to the bottom to have 280. So how many times will 32 go into 280? Well, we know from earlier that 9 times 32 is 310. That's going to be too big, so we're going to have to go with 8. We're going to have to go with 8. So 8 times 30 is 240. 8 times 2 is 16. So 8 times 32 would be 240 plus 16, or 256. And we're going to subtract. Borrow from the 8. This will become 7. This will be 10. 10 minus 6 is 4. Then 7 minus 5 is 2. So I'm going to get 24 there. And let's one more time put a 0 here and bring this down. All the way down. So it's kind of cut off, but the divisor again is 32. How many times will 32 go into 240? Well, at this point, we know that, again, 8 times 32 is what gave us a result of 256. 8's going to be too big. So we got to go one less. We got to go down to 7. We got to go down to 7. And 7 times 32, 7 times 30 is 210. 7 times 2 is 14. 210 plus 14 is going to be 224. So this would be 224. And let's subtract. Borrow from the 4. This will become 3. This will become 10. 10 minus 4 is 6. 3 minus 2 is 1. So I've got 16 now. So let's go back up to the top. Put another 0 and bring this guy down. All the way down. So how many times will 32 go into 160? Well, we have that answer already. In the very beginning, I said 32 times 10 is 320. And then we mentally cut it in half to 160. So half of 10 is 5. So 32 times 5 is 160. That means that 32 will go into 160 exactly 5 times. So 5 times 32 again is 160. And we subtract here and get 0. So go back up to the top and we can write our answer. Let me just kind of erase this and I can just put equals. So 15.9 divided by 3.2 is going to be equal to 4.96875. All right, let's take a look at 16.84 divided by 10 cubed. So again, this is another problem where we're dividing by 10 or a power of 10. If I have 10 as a base and 3 as the exponent, it tells me that I basically have 1,000, right? A 1 followed by 3 zeros. I don't even need to evaluate. I don't even need to know that because all I need to know is if this exponent is 3, I'm taking this decimal point in this number and I'm moving it 3 places to the left. So it's going 1, 2, I'm going to put a 0 in there, and then finally 3 places to the left to give me a final answer here of 0.01684. All right, let's take a look at one final problem. So we have 6.289 divided by 1.1. So again, if I'm dividing by a number that has a visible decimal point here, I just need to move this decimal point 1 place to the right so that it turns it into a whole number. Whatever I do over here to the divisor, I need to also do it to the dividend. So now I'm looking at the division problem. 62.89 divided by 11. So let's set that up. We have 62.89, and again, we're dividing by 11. Now, again, the first thing I'm going to do is I'm going to bring this decimal point up into the answer. That way I can just forget about it and divide as if I had 6,289 divided by 11. So 11 will not go into 6. It will go into 62. It will go in 5 times. 5 times 11 is 55. And we want to subtract. We'll borrow here. This will be 5. This will be 12. 12 minus 5 is 7. We're going to bring down this 8 here. 11 goes into 78 7 times. 7 times 11 is 77. Subtracting, we'll have 1. Go ahead and bring down the 9. 11 will go into 19 only once. 1 times 11 is 11. Subtract here, and we're going to get 8. And now we can put a 0 here and bring that guy down. So how many times will 11 go into 80? Well, it's going to go in 7 times, right? 7 times 11 is 77. So put a 7 there. Again, 7 times 11 is 77. Subtract here, you get 3. And I'm going to go up here and put another 0 there. Bring that down. And I'll have 30. 11 will go into 30 twice. It will go in twice. 2 times 11 is 22. 22. If I subtract, I'm going to get 8. Now, here's where you notice that you have a pattern forming. I had 8 here. It became 80. Now, if I have 8 again, it's going to become 80. And so my pattern is going to repeat itself. So at this point, I could already stop. But we're going to continue for a few more. So put a 0 down and bring it down. Bring it down. How many times will 11 go into 80? The answer to that is 7. So you're going to have another 7 here. And after that, you're going to have a 2. Then a 7, then a 2. So that's what's repeating. It's the 7, 2, 7, 2, 7, 2, so on and so forth. So again, 11 is going to go into 87 times. We put a 7 up there. 7 times 11 is 77. Subtracting, you're going to get 3, right? Which is exactly what we did here. If I brought down another 0 and made this 30, let me do that. Let me put another 0 here and bring that down. I'd say how many times will 11 go into 30? The answer again to that is going to be 2. So here's another 2. 2 times 11 is 22. 22. And if we were to subtract, we get 8 again. So you see you have 8, then 3, then 8, then 3. Or basically you can think about it as, when you bring the 0, you're going to have 80, then 30, 80, then 30. This would be 80, and then it would be 30 again. So that pattern is going to continue forever and ever and ever. So once you realize that, again, you can just erase everything and go ahead and write your answer. Right? You don't need to do anything else. All right, so I'm going to put that this is equal to, I have 5.71, and then what repeats is the 7 and then the 2. So I need to make sure that I put a bar over both the 7 and the 2. And let me make that a little straighter. Because you're basically telling anyone who looks at that that 7 and that 2 repeat forever. And there's more than one way to write that. You could actually just write 5.71, 72, 72, 72, and then, put your 3 dots to say that pattern of having a 7 followed by a 2 will continue forever. This is a little bit better because it's, it's smaller, it's more compact, and it's a little bit more convenient to write. So once again, our answer for 6.289 divided by 1.1 is going to be 5.7172, where the 7 and the 2 repeat forever. Hello and welcome to Pre-Algebra Test Section 1 on dividing decimals. All right, so we just want to find each quotient, and we're going to start out with an easy one. We have 7.5 divided by 3. So to do this, we just set up a long division. So 7.5, and we're dividing by 3. And basically, we just bring our decimal point up into the answer. And once we've done that, we can just divide like if the decimal point didn't even exist. Basically, like we had the problem 75 divided by 3, right? 3 goes into 7 twice. 2 times 3 is 6. Subtracting, you'd have 1. Bring down the 5. 3 goes into 15 5 times. 5 times 3 is 15. Subtracting, you'd have 0. So our answer here for 7.5 divided by 3 is going to be 2.5. And the great thing about division is that you can check it with multiplication. So what you can do, if you're unsure if you got the right answer, go ahead and take your quotient, which is 2.5 in this case, and multiply it by 3. So you're going this way. So 2.5 times 3, the quotient times the divisor, should give you 7.5, the dividend. So I'd do 25 times 3, that's 75. And then I'd put the decimal point one place to the left for every decimal place between the factors. Well, between the two factors, I just have one decimal place. And so I'd move the decimal point one place to the left, and that would give me 7.5, right, which is my dividend. So I know I have the right answer. 7.5 divided by 3 is 2.5. Okay, now we're looking at 18.8 divided by 2. So same thing. We'll just set up the long division. Bring this up into the answer, and we divide like we normally would if we had 188 divided by 2. So 2 does not go into 1, but it does go into 18 9 times. 9 times 2 is 18. Subtracting, you get 0. Bring down the 8. 2 goes into 8 4 times. 4 times 2 is 8. Subtracting, get 0. So our answer here is 9.4. Hello and welcome to Pre-Algebra Test Section 2 on dividing decimals. So we just want to find each quotient. And we're going to start out with 1.8 divided by 1.5. So to perform this operation, what we're going to do is we're going to move the decimal point in the divisor by enough spaces to the right to make it a whole number. So instead of 1.5, I'm going to move this one place to the right and have 15. Now to make this legal, I need to also do it in the dividend. And basically you can kind of think about this as, okay, if I had 1.8 over 1.5 like this, kind of using a fraction that we're familiar with, we could multiply the top and bottom by 10, and we'd have 18 over 15, which is exactly what we're going to have here, 18 divided by 15. So now we can just perform the operation using a long division. So 18, and we're dividing by 15. 15 goes into 18 once. 1 times 15 is 15. Subtracting, you get 3. Now I taught you in the lesson that we could put a decimal point here after the 8, bring that up into the answer, and we could put zeros after that decimal point We're not adding any value to the number. We're just continuing our division. So bring this down. We know that 15 goes into 30 twice. 2 times 15 is 30. Subtracting, you get 0. So our answer here is going to be 1.2. All right, for the next one, we have negative 4.495 divided by 0.31. So I'm going to move this 2 places to the right, and I'm going to match that over here. 2 places to the right. So let's rewrite this problem as negative 449.5 divided by 31. So I already know that negative divided by positive is negative. So now I can just think about absolute values. I can just pretend that both the numbers are positive and do my long division as 449.5 divided by 31. Go ahead and bring this up into the answer, and we could start dividing. 31 does not go into 4, but it does go into 44 once. 1 times 31 is 31. Subtract here, and 4 minus 1 is 3. 4 minus 3 is 1. Go ahead and bring down that 9. How many times will 31 go into 139? Well, 31 times 5 is 155. That's too big. So we're going to have to use 4. 4 times 30 is 120. 4 times 1 is 4. So this would be 4 times 31 would be 124. So subtract here. 9 minus 4 is 5. 3 minus 2 is 1. Of course, 1 minus 1 is 0. We bring down the 5. And as I just said, 31 times 5 is 155. So that tells me that 31 goes into 155 5 times. Again, 5 times 31 is 155. Subtracting, you get 0. Now, go back up to the top. Remember, 14.5 is not our answer because we had a negative divided by a positive. So we need to stick this part next to this part and officially declare that our answer is negative 14.5. Hello and welcome to Pre-Algebra Test Section 3 on dividing decimals. All right, so we just want to find each quotient. And we kind of have two easy problems here. We have 0.0536 divided by 10 cubed. When we divide by 10, or a power of 10, and when I say power of 10, I mean 10 raised to a whole number that's 1 or larger. Basically what you do is you move your decimal point 1 place to the left for every 0 in the power of 10. So in a previous lesson, we learned that when we have 10 as a base and we have a whole number exponent, what we can do is basically write a 1 down and follow the 1 by the exponent number of zeros. So write a 1 and then 1, 2, 3 zeros. The only whole number this isn't going to work for is 0, right? If I have 10 raised to the power of 0, that's just 1. But for everything else, if I have 10 raised to the first power, I can write a 1, follow that with 1 0. If I have 10 squared, I can write a 1 followed by 2 zeros, I have 100. 10 cubed, a 1 followed by 3 zeros, I have 1,000, so on and so forth. Knowing that I'm going to have 3 zeros for 10 cubed, basically I just look at my dividend here, and I can say, okay, all I really need to do is move my decimal point 3 places to the left, because the power of 10 I'm dividing by is going to have 3 zeros in it. So I'm going to write out 3 zeros here, and I'm just going to move this 1, 2, 3 places to the left. And let me kind of clean that up a little bit. So we'd have 0.0000536 as our answer. For the next one, we have the same type of problem. We have 1,786.51 divided by negative 10 million. So first things first, we know that positive divided by negative is a negative. So we can just start out with that. Now the next thing is, if I look at this power of 10 here, forget about the negative sign. If I just look at 10 million, it has 1, 2, 3, 4, 5, 6, 7 zeros. So 10 million is 10 to the 7th power, right? Those are the same. So I know that I'm just going to basically take this number, 1,786.51, and move the decimal point 7 places to the left. So I need to put in 3 zeros here to make that happen. So 1, 2, 3, 4, 5, 6, 7 places to the left. And what I'm going to end up with is a negative 0.0001786, and I need to erase this 5, 1. Okay, so again, a negative 0.000178651. Hello and welcome to Pre-Algebra Test Section 4 on dividing decimals. All right, so we just want to find each quotient. And we're going to begin today with 14.45 divided by 1.5. So when we're dividing with decimals and we encounter this situation where we have a decimal point here in the divisor, what we need to do is move the decimal point over to the right enough places to make that divisor into a whole number. So if I look at 1.5, all I would need to do is move it one place to the right to convert it into the number 15. Now to make this legal, we need to also match this movement in our dividend as well. So I'm going to move this over here, and that's going to create a new division problem for us, which would be 144.5 divided by 15. So we'll set this up using long division format. 15 is going to go out here. 144.5 will go underneath here. And remember, before we begin, we're going to bring that decimal point up into the answer and then divide like it's not even there. So 15 is not going to go into 1. It's not going to go into 14. It will go into 144. Now, to guess at this, I know that 15 times 10 is 150. That's too big. So if I back off 1 and say that the answer is going to be 9, 9 times 15 will give me what? 9 times 5 is 45. Put a 5 down, carry the 4. 9 times 1 is 9, plus 4 is 13. So that would be 135, and that would work out, right? Because when I subtract here, it's going to be less than 15. So I'll borrow here. This will be 3. This will be 4. 14 minus 5 is 9. And we'll go ahead and bring down the next number, which is a 5. How many times will 15 go into 95? Well, mentally, I know that 15 times 4 is 60. So then times 5 would be 75. Times 6 would be 90. So we would put a 6 here. 6 times 15 would be 90. Subtracting, we would get 5. So at this point, we're not done. Remember, we're going to continue our division by putting a 0 after this 5 here and bringing it down so that we can continue. 15 will go into 50 3 times. And 3 times 15 is going to be 45. Subtracting, we get 5. Put another 0 here, bring it down. And we get 50 again. Now 15 will go into 50 3 times. 3 times 15 is 45. So at this point, you can kind of stop and see the pattern that's going on. Right? We'll have an infinitely repeating digit of 3. Because every time I multiply 3 times 15 to get to 45, I subtract it away from 50 and I get 5. I bring down the next 0, I got 50 again. That's going to keep happening. So I'll keep getting 3s forever and ever. Once you recognize that, let's just erase this real quick. Again, as I was saying, once you recognize that, you can go up and just write your answer. It's going to be 9.63, and you put a bar on top of that 3 to say, hey, the 3 is going to continue forever. Let's suppose we have 23.4 divided by 70.2. So again, I've got to make this divisor into a whole number. So I need to move this decimal point one place to the right, and I match that in the dividend. And so the new division problem will be 234 divided by 702. So 234, and we're dividing this by 702. Now, if you notice here, your dividend is smaller than your divisor. So you know that you're going to have to start out by putting a decimal point after the 4, bring that up into the answer, and putting a 0 after your decimal point so that you can kind of expand this. Right? Because if you ask how many times will 702 go into 2, 23, or 234, in each case it's going to be 0. Right? So kind of before we got into dividing decimals, we'd say the answer is 0 with a remainder of 234. But now that we know how to divide decimals, we can use these facts to kind of expand on this and continue our division. So we can ask, how many times will 702 go into 2,340? Well, I know that 700 times 3 would be 2,100. So 702 times 3 would just be 2,106. So that's as close as we can get. So let's put a 3 here to start. Again, 3 times 702 is 2,106. We're going to subtract. Let's borrow from the 4. This will become 3. This will be 10. 10 minus 6 is 4. 3 minus 0 is 3. 3 minus 1 is 2. So that gives me 234. And we could put another 0 and just bring this down and continue. Now, one thing you're going to notice right away is that, okay, I just did 2,340, and now I have 2,340 again. So if I ask the same question, how many times will 702 go into 2,340, I'm going to get the same answer. It's going to be 3. 3 times 702, again, is going to be 2,106. And when I subtract again, borrow from the 4, this becomes 3. 10, 10 minus 6 is 4. 3 minus 0 is 3. 3 minus 1 is 2. Again, I get 234. So I could add another 0 here and bring it down, but again, I get 2,340 this is an infinitely repeating pattern, right? I'm just going to keep getting 3s, right? 3, 3, 3. It's just going to keep going. So you can erase this once you have figured out what the answer is going to be. And simply put, you can just put 0.3 with a bar on top of the 3 to say, hey, this 3 is going to continue forever and ever and ever. Hello and welcome to Pre-Algebra Test Section 5 on dividing decimals. All right, we want to just find each quotient. And we have kind of a long, tedious problem, so we're just going to look at one. So we have negative 5.53 divided by negative 3.333. Now, the first thing you should notice is that you have a negative divided by a negative. Go ahead and just write that the answer is going to be positive. That way you can just think about everything in terms of absolute value, right? You can just treat all the numbers as if they were positive. Now, the next thing is that your divisor is going to need to be converted into a whole number. So we're going to move this decimal point 1, 2, 3 places to the right. And I'm going to match that movement over here in the dividend. 1, 2, 3 places to the right. So we essentially have the problem now, 5,530 divided by 3,333. So let's set that up using a nice little long division. So we have 5,530, again, and we're dividing that by 3,333. Now, to start our division off, we know 3,333 is not going to go into 5, 55, or 553. We'd have to ask, how many times will 3,333 go into 5,530? The answer is only once. So we put a 1 here. We multiply. 1 times anything is itself, so the answer is 3,333. And we're going to subtract. I'm going to borrow from this 3. This will become 2. This will become 10. 10 minus 3 is 7. Then I need to borrow again. So this 5 will become 4. This 2 will become 12. 12 minus 3 is 9. And 4 minus 3 is 1. And 5 minus 3 is 2. So I get 2,197. Now, to continue our division, I can put a decimal point here and bring that up into the answer and put a 0 behind it. Remember, I'm not changing the value of the number. This is just something we're doing to continue our division. So bring down that 0, and I've got 21,970. Okay, so now I'm going to ask a question. How many times will 3,333 go into 21,970? So here's where you have to make kind of an educated guess. If you were to think about the number 3,333 as just 3,000 for a minute, just estimate it to 3,000. If I multiply it by 7, it's easy to do because of the trailing zeros. You're going to get 21,000. Now, think about this part of the number here, 333. Just estimate that to be 300. So what is 300 times 7? Well, that's 3 times 7, or 21. Put 2 zeros at the end, that's 2,100. I can already see this isn't going to work out. This number's too big. 21,000 plus 2,100 is larger than the 21,970 that we're looking for. So even though this is an estimate, it's too big, right? So I know that the actual number where we add another 33 to it is going to be too large. So what we're going to need to do is scale this down and use 6, right? We're going to have to find out what is 3,333 times 6, because that's as close as we can get without going over. 6 times 3 is 18. Put an 8 down, carry the 1. 6 times 3 is 18 again, plus 1 is 19. 9 down, carry the 1. 6 times 3 again is 18, plus 1 is 19. 9 down, carry the 1. 6 times 3 is 18, plus 1 is 19. So that's 19,998. That's going to work out for us. So let's go up here, and we're going to answer this part. This is going to be a 6 here for our answer. Again, for 3,333, how many times that'll go into 21,970? And when we multiply, again, we have that answer down here, 19,998. So I'm going to put 19,998, and I'm going to subtract. So I need to borrow to start. This will become 6. This will become 10. 10 minus 8 is 2. Now I have to borrow again. Borrow from the 9. This will become 8. This will become 16. 16 minus 9 is 7. Got to borrow one more time. Borrow from this 1. This will become 0. This will become 18. 18 minus 9 is 9. Then I'm going to borrow from the 2. This becomes 1. This becomes 10. 10 minus 9 is 1. And 1 minus 1 is 0. So I have 1,972. And I'm just going to put another 0 behind here and bring that guy down so I can continue the division. So now how many times will 3,333 go into 19,720? Well, we can kind of look at our previous answer and kind of figure this out, because if 6 times 3,333 is 19,998, that's going to be too big. It's larger than 19,720. So it has to be one less than 6 or 5 for our answer. So what is 5 times 3,333? So we'll do that down here. 5 times 3 is 15. Put a 5 down, carry the 1. 5 times 3, again, is 15, plus 1 is 16. 6 down, carry the 1. 5 times 3 is 15, plus 1 is 16. 6 down, carry the 1. 5 times 3 is 15, plus 1 is 16. So 16,665. So 16,665. So now we need to subtract. All right. So if I look over here, I can borrow from the 2. This becomes 1. This becomes 10. 10 minus 5 is 5. And I'm going to borrow again. I'm going to borrow from the 7. This will become 6. This will be 11. 11 minus 6 is 5. 6 minus 6 is 0. 9 minus 6 is 3. So I've got 3,055. So let me go back up to the top, put a 0 here, and bring that guy down to give myself 30,550. So let's get a good guess going. How many times will 3,333 go into 30,550? Well, using my trick for multiplying by 10, I know that 3,333 times 10 would just be this number and basically move the decimal point one place to the right. So 33,330. Now that's going to be too big. Now if I adjust my guess to 9, that's going to be right where I need it to be. So let's go back up here, and I'm going to put a 9 here, and I'm going to go back down, and let's figure out what that's going to be, because we need to do 3,333 times 9. 9 times 3 is 27. Put a 7 down, carry the 2. 9 times 3 again is 27. Plus 2 is 29. Put a 9 down, carry the 2. 9 times 3 again is 27. Plus 2 is 29. 9 down, carry the 2. 9 times 3 is 27. Plus 2 is 29. So I get 29,997. So let's go back up to the top. And we have 29,997. So let's go ahead and subtract here. And let me scroll down. I know things are going to get cut off, but we're going to have to fit everything on the screen. So we're going to borrow from the 5. This will be 4. This will be 10. 10 minus 7 is 3. Borrow again. This 5 will become 4. This 4 is 14. 14 minus 9 is 5. And we're going to borrow all the way from this 3. This will be 2. This will need to be 10, then 9, then the 4 will become 14. 14 minus 9 is 5. 9 minus 9 is 0. 2 minus 2 is 0. So I'm going to have 553 now. So let's go up to the top, put another 0 there, and drag it all the way down. So how many times will 3,333 go into 5,530? Well, just once. So now I'm going to multiply. 1 times 3,333 is going to be 3,333. And some of you probably already picked this up, but this is what we started with. 5,530 was the initial starting number, right? It's the initial dividend that we're working with. If I get that again, and I'm subtracting away 3,333, it's the same thing as what I did here to start. Let me just kind of erase this stuff. And you can see that you have 5,530 minus 3,333, and that gave you 2,197. You brought down a 0, and you got 21,970. That's going to repeat itself here, right? If I do the subtraction, borrow from the 3, this will be 2, this will be 10. 10 minus 3 is 7. Borrow from the 5 now. This will become 4, this will become 12. 12 minus 3 is 9. Then 4 minus 3 is 1, and 5 minus 3 is 2. So I've got 2,197. When I go up here to drag a 0 down, I'm going to have 21,970. So as soon as you recognize that you have a repeating pattern, you can go ahead and stop, right? This is 21,970 here. And we found that 3,333 would go into 21,976 times. So I know the next part here would be 6, and then I can just kind of go through and say, okay, well then after that I'd have a 5, a 9, and then a 1. A 6, a 5, a 9, and then a 1. Right? That pattern is going to continue forever. So once you understand that, you can go ahead and just stop. And let's go up here to the top. And I'm going to put equals. And let me just write this in a better way. We have 1.6591. The 6591 is what repeats. So I put a bar on top of the digits that repeat, right? The 6, the 5, the 9, and the 1. Don't put it on anything that's not part of that repeating pattern, right? Because when you look at it, you need to know that, okay, the 6591 repeats. So if I was to kind of look at this, I'd say, okay, that number is 1.6591, 6591, 6591, so on and so forth. I can put 3 dots here to say that pattern would continue forever. Or I can use the bar on top of the digits that repeat. Either way is perfectly mathematically legal. Hello and welcome to Pre-Algebra Practice Set number 44. In this video, we're going to look at some additional practice problems for our lesson on changing fractions to decimals. So we just want to change each fraction into a decimal. And we're going to start out with 7/11ths. So basically the procedure is very, very simple. All you need to do is divide the numerator by the denominator. So we'll take 7, which is our numerator, and divide it by 11, which is our denominator. Now 7 is smaller than 11, so to complete the division, what we're going to do is we're going to put a decimal point after the 7. We're going to bring that up into the answer, and we're going to put a 0 after that decimal point so that we can do 11 into 70 6 times. Now we'd multiply. 6 times 11 is 66. Subtract and you get 4. Now I'd put another 0 here so I can continue my division. So now I'd have 40 here. 11 is going to go into 40 3 times. 3 times 11 is 33. And when I subtract, I'm going to get 7. Now, a lot of you at this point can already tell that there's a pattern that's forming. We started out with a 7, and then we put a 0 behind it, right? Forget about the decimal point, but basically you just have 70 here. So I said 11 goes into 70, and it was 6 times. Then 6 times 11 was 66. We subtracted it, and we got 4. Brought down a 0. 11 goes into 40 3 times. 3 times 11 is 33. When we subtract here, we have 7. So we're repeating that first pattern. So I'm going to have a 6, 3, 6, 3, 6, 3 that continues forever. All right, if I put a 0 here and bring it down, 11 goes into 70 6 times. 6 times 11 is 66. Subtract and I get 4. Right, I'm right back here. If I take a 0 and bring it down, I'd have a 40. 11 goes into 40 3 times. 3 times 11 is 33. Subtract and you get 7. Right, it's just the pattern that continues forever and ever and ever. So when this occurs, basically what we're going to do, we'll write 0.63. 63 are my digits that repeat. So I'm going to put a horizontal bar over the 6 and the 3 to say that these digits will repeat forever. So again, my final answer is that 7/11ths is equal to 0.63, where the 6 and the 3 are going to repeat forever. All right, for the next one, we have 5/8. Again, I'm going to take 5 and I'm going to divide it by 8. 5 is smaller than 8, so I'm going to put my decimal point after 5, bring it up into the answer, and I'll put a 0 after that decimal point. 8's now going to go into 50 6 times. 6 times 8 is 48. Subtract and you would get 2. Now I can put a 0 here so I can continue my division. So now 8's going to go into 20 twice. 2 times 8 is 16. And when I subtract, I'm going to get 4. Put a 0 here, bring it down. 8's going to go into 40 exactly 5 times. 5 times 8 is 40. Subtract and we're going to get 0. So we have our answer here. It's nice and clean. We're going to have 5/8 is equal to 0.625. All right, what about 3/11ths? So again, I'm going to take 3, my numerator, and I'm going to divide that by 11, my denominator. I'll take the decimal point and put it after the 3. Bring it up into the answer and put a 0 after that decimal point. So 11 will go into 30 twice. 2 times 11 is 22. Subtract and we'll get 8. Put another 0 here and bring it down. 11 is going to go into 87 times. 7 times 11 is 77. Subtract and we'll get 3. So you see the pattern that's forming, right? If I put a 0 here and bring it down, I'm going to have 30 again, which is what I started with basically. Right? I started this problem by saying 11 goes into 30 twice. 2 times 11 is 22, so on and so forth. So if I do that again, 11 is going to go into 30 twice. 2 times 11 is 22. Subtract and you get 8. If you bring down another 0, 11 would go into 80 7 times. Again, 7 times 11 is 77. Subtracting, you get 3, right? So you see the pattern that's forming. You have 80 here, then 30. Then you have 80 again, so then this would be 30 after I bring down my 0. You know, so on and so forth. So we already have our answer. And once you spot the pattern, you can just stop. Right? You can just say this is equal to 0.27, right? It's 27, 27, 27, so on and so forth. So the 2 and the 7 are what's repeating. So I'm going to put a horizontal bar over both the 2 and the 7 to indicate that. Again, 3/11 is equal to 0.27, where the 2 and 7 repeat forever. All right, let's take a look at 12 and 11/16. So this is a mixed number, and it's not any more difficult. Basically, what you're doing is this part right here, the whole number part, you just write it out to the left of the decimal point. Now, after the decimal point, we're just going to have this part right here, the fractional part, the part of a whole amount expressed as a decimal, right? That's all we're going to have. So we're going to figure out what 11 divided by 16 is, and that's going to help us fill in this part right here. So I'm going to put a decimal point after 11, bring that up into the answer, put a 0 after that decimal point. 16 will go into 110 how many times? I know that 16 times 10 is 160. Let's start with that. That is obviously too big. Now, if I cut it in half, what is 16 times 5? Half of 160 is 80. That's too small. If I add 16 more to 80, I would get to 96. So 16 times 6 is 96. That looks like that's going to be just about as large as we can go without going over. So I'm going to put a 6 here, and I'm going to multiply. 6 times 16 again is 96. We're going to subtract, and I'm going to borrow from this 1. This will be 0. This will be 10. 10 minus 6 is 4. And I'm going to borrow again from this 1. This will be 0. This will be 10. 10 minus 9 is 1. So I'm going to have 14. And of course, I can put a 0 here so I can continue my division. Go ahead and bring this down. Now, I know that 16 times 10, again, is 160. If I subtract 16 away from that, I'm still going to be too large. I'm going to be at 144. So 16 times 9 doesn't work. It's going to have to be 16 times 8. Right? It's going to have to be 8 as an answer here. 8 times 16, you can do 8 times 10. That's 80. 8 times 6 is 48. Then 80 plus 48 is 128. Subtract here. I'm going to borrow from that 4. This will become 3, and this will become 10. 10 minus 8 is 2. 3 minus 2 is 1, so I'm going to have 12 there. I'm going to put a 0, bring it down. 16 goes into 120. Well, I know 8 is too large. I'm going to have to go with 7. What is 7 times 16 now? Well, 7 times 10 is 70. 7 times 6 is 42. 70 plus 42 is 112. So we're going to subtract, and we're going to get 8. And let me go back up to the top. We're going to take one more 0 and bring that all the way down. All the way down. So that we have 80. And so we're going to ask, how many times will 16 go into 80? Well, if you paid attention, again, I did 16 times 10, that was 160. I cut it in half, and I found that 16 times 5 was 80. So 16 will go into 80 exactly 5 times. 5 times 16, again, is 80. Subtracting, you get 0. So this part right here, this 0.6875, is representing this fraction part for the mixed number, the 11/16. So I've already written the whole number part, the 12. Basically, after it, I'm just going to write 0.6875. I already have my decimal point there, so I'm just going to write 6875 behind it. And so 12 and 11/16 is equal to 12.6875. Okay, let's look at one final problem. So here we have an improper fraction. We have 27/8. But again, we attack the problem the same way. We take 27 and we divide by 8. Now, 8's not going to go into 2, but we'll go into 27 3 times. 3 times 8 is 24. Subtracting, you get 3. I can put a decimal point here so I can continue my division. Bring that up into the answer. Put a 0 here and bring it down. 8's going to go into 30. Again, 3 times. 3 times 8 is 24. If we subtract here, we're going to get 6. Put a 0 here and bring it down. 8's going to go into 60 7 times. 7 times 8 is going to be 56. If we subtract here, we're going to get 4. Let's put another 0 and bring that guy down. So that's going to be 40 now. And we're asking how many times will 8 go into 40? Well, the answer is exactly 5. Right? Exactly 5 times. 5 times 8 is 40. Subtracting gets 0. So 27/8 is going to be equal to 3.375. Hello and welcome to Pre-Algebra Test Section 1 on changing fractions to decimals. So we want to change each fraction into a decimal. And we're going to start out with 9/11ths. And essentially what we do here is just divide the numerator by the denominator. Right? So we're going to take 9 and we're going to divide it by 11. And since 9 is smaller than 11, what I'm going to do is put a decimal point after 9, bring it up into the answer. I'll put a 0 after the decimal point. And I can ask, how many times will 11 go into 90? Well, it's going to go in 8 times. 8 times 11 is 88. Subtract, and now we get 2. Put another 0 to continue the division. Go ahead and bring that down. We'd ask, how many times will 11 go into 20 now? Well, 11 is going to go into 20 only once. 1 times 11 is 11. Subtract, and we would get 9. Now, we started out with a 9, and then we put a decimal point, and we put a 0 behind it. So we asked, how many times will 11 go into 90? It's exactly what we're going to ask again, right? We're going to put a 0 here and bring it down. And we're going to ask, how many times will 11 go into 90? Well, we know the answer is 8. 8 times 11 is 88. Subtract, and you're going to get 2. So you see that you have a pattern forming. If I put a 0 here and bring it down, I have 20 again. Right? I had 90, then 20, then 90, then 20. So I know 11 goes into 20 only once. 1 times 11 is 11. Subtract here, and I'm going to get 9 again. If I brought down another 0, I would get 90 again. So the pattern is that I have 8, 1, 8, 1, 8, 1. That will continue forever, right? So we're going to write that 9/11ths is equal to 0.81. And it's very important that we put a horizontal bar over the 8 and the 1 to indicate that the 8 and the 1, that pattern is going to continue forever. All right, let's take a look at another one. We have 3/5. So we're going to write 3 divided by 5 like that. And again, 3 is smaller than 5, so I'm going to put a decimal point after 3. I'm going to bring that up into the answer, and I'm going to put a 0 after my decimal point. So how many times will 5 go into 30? Well, it goes in exactly 6 times. 6 times 5 is 30. Subtract, and you get 0. So 3/5 is going to be equal to 0.6. Hello and welcome to Pre-Algebra Test Section 2 on changing fractions to decimals. All right, so we want to just change each fraction into a decimal. And we're only going to look at one problem here, just because this problem is going to be pretty tedious. So we have 2/111. So to change this fraction into a decimal, we're going to divide the numerator, which is 2, by the denominator, 111. So 2 divided by 111. Now, in order to complete this division, I'm going to need to put a decimal point after 2, bring it up into the answer, and put a 0 here. Now 111 is still not going to go into 20. I'm going to need to put another 0 here in order to complete the division. But there's one kind of problem here. If I say 111 doesn't go into 2, I can put a 0 and kind of go through the steps, but it's not really adding any value to the number, right? If I have a 0 to the left of the decimal point, I don't really need to put it because it doesn't really make a difference. In this particular case, after the decimal point, the 0 is going to matter if we have a non-zero digit that follows it. And we know that we're going to have that. So we're going to go ahead and say that 111 does not go into 20. So we're going to put 0 here and go through the steps. 0 times 111 is 0. If I subtract, I'm going to get 20. Now I can put my 0 here and bring that down, and I have 200. So 111 will go into 200 only once. 1 times 111 is 111. If we subtract, I need to borrow all the way from this 2. This will be 1, this will be 10, then 9, then 10. 10 minus 1 is 9. 9 minus 1 is 8. 1 minus 1 is 0. So now I'm going to put a 0 here and bring that down. How many times will 111 go into 890? Well, if I multiply 8 times this number consists of all ones, so it's easy to do, right? It's going to be 888. 888 is just underneath 890, so that's going to work out. So I'm going to put an 8 here. Again, 8 times 111 is 888. subtract, and I know I'm going to get 2. Now, when I bring down a 0 here, I have 20 again. Remember, I started out with 20, and 111 is not going to go into 20. 20 is smaller than 111. So that gives me a 0 again. Now, 0 times 111 is going to give me 0. I subtract, and I get 20. I bring down a 0 from the top, and I get 200. That's exactly what I had here, right? I had 20, then 200, then 890. The same pattern is forming, right? 111 is going to go into 200 once. 1 times 111 is 111. If we subtract, again, it would be 89. If I bring down another 0, it would be 890. So at this point, I can stop. I already know what the pattern is going to be. It's going to be 0, 1, 8, right? 0, 1, 8, 0, 1, 8, 0, 1, 8, so on and so forth. So I can say this is equal to 0.0, and that 0 is important, right? It adds value to the number because it is before that 1 and that 8, right? So 0.018, where there's a horizontal bar on top of the 0, the 1, and the 8, because those are the digits that are going to repeat in that order forever. Hello and welcome to Pre-Algebra Test Section 3 on changing fractions to decimals. All right, so we want to change each fraction into a decimal. And for our first problem here, we're going to look at the mixed number 15 1/8. And basically, when you have a mixed number, all you're really doing is you're taking the whole number part and you're going to write it. You're going to put your decimal point, and then after the decimal point is going to come this part expressed as a decimal. Right, so we would just figure out what 1/8 is. And to do that, we divide 1, the numerator of the fraction 1/8, by 8, the denominator of the fraction 1/8. So 1 is smaller than 8, so what I can do to make this division work, I'm going to put a decimal point here, bring it up into the answer, put a 0 after that decimal point, and now I can ask, how many times will 8 go into 10? 8's going to go into 10 once. 1 times 8 is 8. Subtract here and you would get 2. I can put another 0 so I can continue my division. So now I would have 20. 8 goes into 20 twice. 2 times 8 is going to give me 16. 16. Subtract and I would get 4. Let's come up here and put another 0 and bring that down. So I'd have 40 now. 8's going to go into 40 exactly 5 times. So this is going to be a 5 here. 5 times 8 is going to give me 40. Subtract and I have 0. So I know that 1/8 is 0.125. So I have 15 1/8. So I'm just going to write 15 point and then the 125. So 0.125. Again, 15 1/8 is equal to 15.125. Okay, now we're going to look at another mixed number. We have 19 and 5/22. So again, the whole number part, just leave that alone. And we'll put a decimal point after that. And we're just going to figure out what 5/22 is as a decimal. So I'm going to divide 5, the numerator, by 22, the denominator. 5 is smaller than 22, so I'm going to put a decimal point after my 5, bring that up into the answer. And I'm going to put a 0 after that decimal point. And now I'm going to ask the question, how many times will 22 go into 50? Well, it's going to go in twice. 2 times 22 is 44. Subtract, and we're going to get 6. We'll put a 0 here so we can continue our division. Go ahead and bring that down. 22 is going to go into 60, still only twice. 2 times 22 is 44. Subtract here and we get 16. Put a 0 here and bring that down. How many times will 22 go into 160? Well, let's look at that on a scratch sheet. If I estimate 22 as 20, and let's say I multiply it by 8, that would give me 160 exactly. Now I know I'm not going to be able to use 8 because the actual number is 22. So that would be a little bit too big. So let's try 22 times 7 and see if that gets us as close to 160 as we can without going over. 7 times 2 is 14. Put a 4 down, carry the 1. 7 times 2 again is 14 plus 1 is 15. So 154. That looks like that's going to work out for us. So we're going to put 7 down as the answer. So we're going to put a 7 here. Again, that's 22 into 160. That's going to go 7 times. 7 times 22, as we just found, was 154. And if we subtract, we're going to get 6. Now you can start to see what pattern's developing because I had a 6 here, right? So if I put a 0 here and I bring it down, I'm going to have 60 again. So the pattern that's developing, if I say 22 goes into 60, it's only going to go twice. 2 times 22 is 44. Subtract, and I'm going to get 16. Right? I'm right back here. If I put a 0 and bring it down, I'm going to have 160 again. So the pattern is going to be that you have 2, 7, 2, 7, 2, 7, 2, 7. Basically, that's going to repeat forever and ever and ever. So remember, you have this other 2 out here, though. Let's be careful about when we write this. So we have our whole number part already, this 19 here. And then we have our decimal point. So basically what we're going to do is write the part that's after the decimal point here. We have a 2. And then we have that repeating pattern that's 2, 7. Now, I'm going to put a horizontal bar on top of the 2 and the 7. I'm not going to put it on this 2 because that doesn't repeat. Just this 2 and this 7. I've got a 2 that doesn't repeat, and then a 2 that does, and then a 7 that does. So in other words, after this 7 would come a 2 again, but not a second 2. It would be just a 1, 2, and then a 7. 2, 7, 2, 7. That's the pattern that's repeating forever. So you have to be very, very careful when you get duplicate numbers like that, not to make a silly mistake and say, okay, this is what's going to repeat forever. No, it's just this 2 and this 7. Right? So you put your horizontal bar over those 2 numbers only. And again, our answer here is that 19 and 5 over 22 is equal to 19.2. Then 2, 7, where this 2 and this 7 repeat forever. Hello and welcome to Pre-Algebra Test Section 4 on changing fractions to decimals. All right, we want to change each fraction into a decimal. And we're looking at the improper fraction 24/5 to start. So essentially, I'm going to just divide the numerator by the denominator here. So what is 24 divided by 5? So 5 is not going to go into 2, but it'll go into 24 4 times. 4 times 5 is 20. Subtract and you get 4. Now in the past, this is where we stopped, right? We'd write this as a mixed number that's 4 4/5. But here we're going to put a decimal point after the 4, bring that up into the answer, put a 0 after it, and bring that down so we can continue our division. 5 is going to go into 48 times. 8 times 5 is 40. Subtract and get 0. So 24/5 is going to be equal to 4.8. Or again, if we were talking about mixed numbers, it would be 4 4/5, right? All of these are different forms of the same number. All right, let's take a look at another one. So I have 231 over 9. So again, I'm going to divide 231 by 9. 9 is not going to go into 2, but it'll go into 23 twice. 2 times 9 is 18. If we subtract here, we would get 5. Right? I could borrow. This would be 13 minus 8. That's 5. Go ahead and bring down this 1 here. 9 will go into 51 5 times. Right? 5 times 9 is going to be 45. If we were to subtract here, we would get 6. Right? I could borrow here. This would be 4. This would be 11. 11 minus 5 is 6. Now, to continue this division, I can put a decimal point here, bring it up into the answer, and put a 0 here, and bring that down. So now I would ask the question, how many times will 9 go into 60? Well, it'd go in 6 times, right? 6 times 9 is 54. 54. But when we subtract, we get 6 again, right? If I put a 0 here and bring that down again, I'd have 60 again. 9 is going to go into 60 6 times. 6 times 9 is 54. If I subtract, I get 6 again. So this 6 is going to repeat forever and ever and ever. So we're going to stop now that we realize that pattern and say 231 over 9 is going to be equal to 25.6. And we put a horizontal bar over the 6 to indicate that the 6 is going to repeat forever. Hello and welcome to Pre-Algebra Test Section 5 on changing fractions to decimals. All right, so we want to change each fraction into a decimal. And we're going to start out with this mixed number 11 and 3/16. So basically what we're going to do, we're going to take the whole number part of the mixed number and just write it. And you'd have a decimal point after it. And then you'd have basically this value here, right? 3/16 as a decimal, you'd have point and then some value, right? So we write the whole number part and then point and then some value just to express this 3/16 amount here. So to figure out what 3/16 is as a decimal, we just divide 3, the numerator, by 16, which is the denominator. Now, 3 is smaller than 16, so essentially what we're going to do is we're going to put a decimal point after the 3, bring it up into the answer, and put a 0 after that decimal point so we can crank out the division. So 16 is now going to go into 30 once. 1 times 16 is 16. If we subtract, I could borrow here. This will be 2, this will be 10. 10 minus 6 is 4. 2 minus 1 is 1. I'm going to have 14. Now we're going to add a 0, bring that down, and I'm going to have 140. So 16 will go into 140. We know 10 is too big. 16 times 10 is 160. If I subtract 16 away from that, in other words, if I was doing 16 times 9, I'd have 144. That's still too big. So we're going to have to go with 8. 8 times 16. 8 times 6 is 48. Put an 8 down, carry the 4. 8 times 1 is 8, plus 4 is 12. So that's going to be 128. So let's subtract here. And basically, you borrow from this 4, you're going to have 3. This will become 10. 10 minus 8 is 2. 3 minus 2 is 1. And so I'm going to have 12. Now I can put another 0 and bring this down. And I'm going to have 120. Now, if 16 times 8 is 128, I know that 8 is going to be too large. You're going to have to go with 7. Now, 7 times 16. 7 times 6 is 42. 2 down, carry the 4. 7 times 1 is 7, plus 4 is 11. So that's going to be 112. And we subtract here and borrow. 10 minus 2 is 8. And that's all going to be 0. So we have an 8 there. Put a 0 and bring that down. And then I have 16 goes into 80. That's going to be exactly 5 times, right? 5 times 16 is 80. So we subtract here and get 0. So basically, to write this, again, we have our whole number part, which is 11. And then we'll have the point and then 1875, right? This is the part here that comes after the 11, the 0.1875. It's the same thing as the 3/16, just as a decimal. So 0.1875. So 11 and 3/16 is equal to 11.1875. All right, let's take a look at 3 4/5. So again, this whole number part here, 3, is just going to go out in front. I'm going to put my decimal point. And then what is 4/5 as a decimal? Well, I'm going to do 4 divided by 5. And 4 is smaller than 5, so I'm going to put a decimal point here. Bring that up into the answer and put a 0 here. 5 is going to go into 40 exactly 8 times. 8 times 5 is 40. Subtract and you get 0. So the whole number part is 3. And then 4/5 as a decimal is 0.8. So I'm going to put 3.8. So 3 4/5 is equal to 3.8. Hello and welcome to Pre-Algebra Practice Set number 45. In this video, we're going to look at some additional practice problems for our lesson on percents. All right, so we just want to start out with a very simple exercise. We want to write each as a percent. So we're going to be dealing with decimals in each case. And to take a decimal and turn it into a percent, you just take the decimal point, move it 2 places to the right, and then you just put a percentage symbol at the end of the number. So we're going to start out with 0.213. So let me just rewrite this number. So 0.213. And all I need to do is take the decimal point and move it 2 places to the right. So it's going to end up right there. And then I'll put a percentage symbol at the end of the number. So I can erase this decimal point here. I don't need this 0. It doesn't add any value to the number. So 0.213 is equal to 21.3%. Okay, for the next one, we have 3.146. So I'm going to rewrite the number, 3.146. Again, all I need to do is take my decimal point and move it 2 places to the right. So it's going to go right there. And then I'm going to put a percentage symbol behind the number. So let's erase that. And we can say that 3.146 is equal to 314.6%. All right, let's look at another one. We have 0.089, and this is going to be equal to, let's rewrite that, 0.089. I'm just going to take my decimal point and move it 2 places to the right. So it's going to go right there. Throw in my percentage symbol at the end, and I'm done. Now I can erase these 2 zeros because they don't add any value to the number. 0.089 is equal to 8.9%. All right, let's look at 0.127. Again, just copy the number. So 0.127. And I'm just going to move this decimal point 2 places to the right and put my percentage symbol at the end. So let's erase all of this. I can erase the 0 too because it adds no value to the number. So 0.127 is equal to 12.7%. All right, let's look at 0.000539. So let's copy this number. So 0.000539. 0.000539. Okay, so once again, I'm going to take this decimal point and go 1, 2 places to the right, and put a percentage symbol at the end. So let me erase all of this. Now I'm going to keep 1 0 in front of the decimal point just for clarity. So 0.000539 is equal to 0.0539%. All right, so we kind of dealt with the easier scenario there. And now let's look at one that's a little bit more challenging, but still pretty easy overall. If you have a fraction and you want to change it into a percentage, well, first off, a percent is a fraction. It's just a fraction where the denominator is 100. So we have kind of two options here. One of the options is to convert this fraction into an equivalent fraction where the denominator is 100. So if I look at my denominator and I see that it's a 2, everybody pretty much knows that you can multiply 2 times 50 and get to 100. So I can multiply 3/2 by 50 over 50. Remember, this is just 1, so it's not changing the value of the number. 3 times 50 is 150, and 2 times 50 is 100. Now, once I have this as a percent, again, that's a fraction where the denominator is 100. That's exactly what we have here. All you need to do is take the numerator, which is 150 in this case, and follow it with a percentage symbol. So 3/2 is equal to 150 over 100, which is equal to 150%. The other way to do this, which in a lot of cases is going to be more time consuming, more tedious, is just to do a division, right? If you take your fraction, convert it into a decimal by doing a division, right? Divide the numerator by the denominator. And then once you have a decimal, you can just move the decimal point 2 places to the right and put a percentage symbol at the end to have a percent. So I would do 3 divided by 2. And 2 will go into 3. It'll go in once. 1 times 2 is 2. Subtract, then I'd have 1. Put my decimal point here and bring it up into the answer. Put a 0 at the end and bring that down. 2 will go into 10 exactly 5 times. 5 times 2 is 10. Subtract here and we get 0. So you see we have 1.5. So 3/2 as a decimal is 1.5. And then to convert it into a percentage, again, all I need to do is take this decimal point and move it 2 places to the right. So 1, put a 0 there, 2. And so I'd have 150, and then put the percentage symbol at the end, 150%. So notice how your answers here are the same, right? 150% and 150%. We just got to that result in a different way. And for some of you, this is going to be easier. For some of you, this is going to be easier. It doesn't really matter as long as you get the right answer, right? So you can do your division, convert it into a decimal, then into a percentage, or you can just figure out what number you need to multiply the denominator by to get a denominator of 100, right? Multiply numerator and denominator by that number so it's legal. And then take your numerator, write that down, and follow it with a percentage symbol. All right, what about 2/25 or 2 over 25? Again, I know that 25 times 4 would give me 100. So the easy way to do this would just be to say, okay, if I multiply the denominator by 4, I'll get a denominator of 100. So if I do this to the denominator, I also have to do it to the numerator. 2 times 4 would give me 8. So 2 over 25 is equal to 8 over 100. As a percentage, remember, if we have a denominator of 100, we have a percent. So all I need to do is take my numerator and write 8 and then follow it with a percentage symbol. So 8 over 100 is just 8%, right? It's parts per 100. I have 8 parts per 100. That's 8%. Again, the other way to do this is to divide 2 by 25 and put it in decimal form. So 2 divided by 25. Of course, I'm going to need to put a decimal point there and bring it up. And this 1 0 is not going to do it, right? Because 25 doesn't go into 2. It's not going to go into 20 either. But remember, because this 0 is going to matter, I have to write it in. This 0 here doesn't matter. I can just skip over. But this one does. So I need to go through the steps and say, okay, well, 0 is going to multiply by 25 and give me 0. Subtract here. 20 minus 0 is going to give me 20. I put another 0 so I can continue my division and bring that down. Now 25 is going to go into 200 8 times. So 8 times 25 is going to give me 200. Subtract and we get 0. So we have 0.08. Okay, 0.08. So let's remember that. So 2 over 25 in decimal form is 0.08. So then as a percentage, 0.08, I just move this 2 places to the right. So I would have just the number 8, right? I don't need that 0 out in front. And I can erase the visible decimal point. We all know it's there. Just put my percentage symbol at the end. And again, I have 8%, right? That's exactly what I got here. Again, 2 methods to achieve the same result. Okay, let's take a look at another one. Let's say we have 1/5. So again, this is another easy one where you can just say, okay, 5 times 20 would give me 100. So I can multiply the numerator and denominator by 20. Right? You're just trying to get the denominator to be 100. So once I figure out what that number is, it's really pretty simple. 1 times 20 is 20. Over 5 times 20, that's 100. So I have 20 over 100. Again, this is a percent. I have 20 parts out of 100. So we can just simply take the numerator, which is 20, and follow that up with a percentage sign, right? 20%, 20 parts, again, out of 100. Now, the other way to do this, again, is to take 1 and divide it by 5. You can put a decimal point here and bring it up into the answer. Put a 0. 5 is going to not go into 1, but it will go into 10 twice. 2 times 5 is 10. Subtracting gets 0. So I have 0.2. 0.2 as a decimal. Now, we'll take 1/5. Write that as 0.2 or 0.2, however you want to write it. And then move that decimal point 2 places to the right. So 1, put a 0 in, and then 2. And then put your percentage symbol after. And again, you're going to end up with 20%. Right? 2 methods to achieve the same result, 20%. All right, let's take a look at one where it's going to be a little quicker to not convert the fraction into an equivalent fraction where 100 is the denominator. So we have 9/16. So let's start out by just dividing the numerator by the denominator to put it in decimal form. So what is 9 divided by 16? Of course, 9 is smaller than 16, so I need to put a decimal point here. Bring that up into the answer. Put a 0 behind it. 16 will go into 90 5 times. And when we multiply, we can use a little mental trick. So essentially, 5 times 10 is what? That's 50. You can do that in your head. 5 times 6 is 30. So 50 plus 30 is 80, right? Quick way to do that in your head. Subtract here, we would get 10. Put a 0 and bring it down. So now we have 100. So if 5 times 16 is 80, if I took 80 and I added 16 to it, I get 96. So that means that 16 times 6 is 96. So 6 is going to be as close as we can get without going over 100. So 6 times 16 is 96. Subtract now and I get 4. Let me scroll down and get a little room going. I'm going to put another 0 here and bring that down. So now we're dealing with 40. I know that 16 times 2 is 32. It's as good as we can do, right? If we go higher, we're going to go over. So 16 goes into 40 twice. 2 times 16 is, again, 32. Subtract, and we would get 8. Put a 0 here and bring that guy down. We'd have 80. 16 is going to go into 80 exactly 5 times. 5 times 16 is 80. Subtracting gets 0. Okay, so we have our answer in decimal form. So 9/16 is equal to, I'm going to put 0.5625. Okay, so once we have this in decimal form, it's pretty easy to convert it to a percentage. Take your decimal point and move it 2 places to the right. So this would be 56.25, and then just put your percentage symbol in. So 9/16 is equal to 0.5625, which is equal to 56.25%. Let me just erase that stuff. Now, why did I say it was easier to do it this way? In most cases, it's easier to do it the other way. Well, what happens is when you can't multiply your denominator by a whole number and get it to 100, so in other words, 16 times no whole number will equal 100, you kind of run into some problems. And I'm not saying that it's impossible to do. You can definitely do it. It's just a little bit more tedious. So if I say 16 times what gives me 100, I can go backwards and say 100 divided by 16 gives me what? Well, we could do that division, but by the time I do that division, I already could have done this division, and I'm done with the problem. So that's why in this case it's a little bit faster to do it the other way. To save ourselves a little bit of time, 100 divided by 16 is 6.25. 6.25. And there are different forms that you can write that in. You could also say that it's 25 fourths or 6 1/4. However you want to write that number. But I would also do that up here, 6.25. And now 16 times 6.25, we know that's 100. So we don't have to do that calculation. But now I have to do another calculation where I have to multiply 9 times 6.25. And of course, if I do that, I'm going to get 56.25. And yeah, I can just take 56.25 now and write a percentage symbol after it. And I have my answer. It's the same either way, but this way would have been a little bit more tedious, right? I had to go through and do a division here. Then once that division was done, I had to do a multiplication with decimals, and it just would have taken more time than just to do this division here, then move the decimal point 2 places to the right, and put my percentage symbol in. So that's why you kind of have to have a little bit of experience with working these problems to know what method you're going to use in what situation. The general rule I'm going to give you is that if you can't take your denominator and multiply it by a whole number to get to 100, go ahead and just divide the numerator by the denominator, put it as a decimal, then convert the decimal to a percentage. It's going to be faster most of the time. Okay, so now let's look at writing a percent as a decimal. So we're just going backwards now. So we want to write each percent as a decimal. And we're going to start out with 0.035%. And essentially all I got to do, let's rewrite this number, 0.035%, is delete your percentage symbol, because you don't need that anymore. And now, instead of going to the right 2 places with your decimal point, you're going to go to the left. So this is going to go 1, and I'll put a 0 in here, and then a second place to the left. So my decimal point is going to be there. And so 0.035% is equal to 0.00035. Right? I can just delete this all together. All right, so something like 0.17%. Again, let's rewrite this, 0.17. And I'm just not going to write the percentage symbol. You can write it and then delete it if you want, but let's just save a little time and just not write it. Okay, so again, I'm going to move my decimal point 1, and I need to put a 0 in. Let me kind of move this equal sign over, a little bit cramped in there. And then I'm going to put another place to the left. So I'm going to end up with 0.17% is equal to 0.0017. Let me write that a little bit lower. Again, 0.0017. Okay, we also have 6.23%. Again, we're going to rewrite that, 6.23. Just leave the percent sign off. You don't need it. And again, go ahead and move this 2 places to the left. I'll put a 0 in. So we'll be right there. And so 6.23% is equal to 0.0623. All right, what about 954.89%? Again, I'm going to rewrite the number, 954.89. Leave the percentage symbol off. And again, I'm taking this decimal point 2 places to the left now, and it's going to end up right here. So we'll end up with 9.5489, right? So 954.89% is equal to 9.5489. All right, for the final problem, we have 0.0274%. And again, I'm just going to rewrite this, 0.0274. Leave the percent sign off. Let me kind of scoot this over a little bit, because I know I'm going to have to add a 0 in, so let me just do that now. And let's move this 2 places to the left. So 1, 2, and there's my decimal point now. And I'll end up with 0.0274% is equal to 0.000274. Hello and welcome to Pre-Algebra Test Section 1 on percents. All right, so we want to convert each to a percent. And we're going to start out with 0.6417. So essentially, if we have a decimal and we want to go to a percent, all we need to do is move our decimal point 2 places to the right and put a percentage symbol at the end. So let's rewrite this number, 0.6417. And I'm just going to circle my decimal point here so it's nice and visible. And I'm just going to move it 2 places to the right. So 1, 2 places to the right. So that's going to go right there. And I'm going to put a percentage symbol at the end. Now let me erase all this and erase my old decimal point. And of course I erase that 0 there because it adds no value to the number. Right? If I put a 0 in front of that 6, it doesn't change the value. So 0.6417 is equal to 64.17%. All right, we're looking at 3.185 now. Again, all I'm going to do is copy the number, so 3.185. And I'm just going to move my decimal point again 2 places to the right. So this is going to go 1, 2 places to the right. And I'm going to put a percentage symbol at the end of the number. So let's delete all of this. And so we can say that 3.185 is equal to 318.5%. All right, for the last problem, we have 0.00092. Again, let's write this as a percentage. So let's copy 0.00092. Again, all I want to do is take my decimal point and move it 1, 2 places to the right. So it's going to go right there and put a percentage symbol at the end of the number. Of course, I can delete these zeros here. They add no value to the number, and the old decimal point. Now, in a lot of cases, I like to put a 0 out in front of the decimal point just for clarity. So we can say that 0.00092 is equal to 0.092%. Hello and welcome to Pre-Algebra Test Section 2 on percents. All right, we just want to convert each to a percent. And we're going to start out with 0.034. So if we want to take a decimal and convert it to a percent, it's very, very simple. We're just going to take our number and rewrite it, so 0.034. We will take our decimal point and move it 2 places to the right. So it would go 1, 2 places to the right, so it would be right there. And then we'll put a percentage symbol behind the number. So the percentage symbol looks like this. And so once we erase the old decimal point, and of course these 2 zeros in front of 3 don't add any value, so we can erase those, we'd end up with 3.4%. So 0.034 is equal to, again, 3.4%. Okay, let's look at 0.298 now. Again, I'll just copy this number, 0.298. And I'm just going to take my decimal point again and move it 2 places to the right. So 1, 2 places to the right, so it's going to go right there. And I'm going to put a percentage symbol after that 8. Let me just erase all of this. I don't need that 0 either. So 0.298 is equal to 29.8%. All right, now we have 0.00037. Again, all I'm going to do is just rewrite the number, 0.00037. I'm going to take my decimal point and go 1, 2 places to the right so that it goes right there. Put my percentage symbol at the end. Let's just erase all these zeros. They don't really matter. And if you want, you can put a 0 out in front of the decimal point. It doesn't really matter. So 0.00037 is equal to 0.037%. Hello and welcome to Pre-Algebra Test Section 3 on percents. All right, so we want to convert each to a percent. And we're going to start out with 1/2. So we have 1/2. Now, when you go from a decimal to a percent, it's very, very easy. When you take a fraction and you go to a percent, it's somewhat more complicated, right? Or I wouldn't say complicated, it's somewhat more tedious because sometimes you have a lot of work to do. In this particular case, when you have a fraction where you can multiply the denominator, which in this case is 2, by a whole number and get to 100, you basically have an easy problem. So I know that 2 times 50 is 100, right? So if I multiply the denominator by 50 and the numerator by 50, I now get a fraction that is a percent. 1 times 50 is 50. Over 2 times 50, that's 100. Remember from the lesson that the definition of a percent is a fraction where the denominator is 100. It means parts per 100. So I have 50 parts per 100, or the number 50, which is our numerator, percent. Right? So when you have a denominator of 100, just take your numerator, which in this case is 50, follow it up with a percentage symbol, and you have your answer. Now, kind of the other way to do this, kind of the more tedious method, is to divide 1 by 2. Right, we're basically taking the fraction and writing it as a decimal. So I'll put a decimal point here and bring it up into the answer and put a 0 here. 2 goes into 10 5 times. 5 times 2 is 10. Subtract and get 0. So I'd have 0.5. 1/2 is equal to 0.5 in decimal form. So then as a percentage, I would move that decimal point 2 places to the right. So 1, 2 places to the right. And so I can actually delete both of these because I don't need to display a decimal point there. We know that it's there. And I can just put a percentage symbol at the end. And so 1/2 is equal to 0.5, which is also equal to 50%. So just basically 2 different ways to achieve the same result. This way here was a lot quicker because we had a whole number that we could multiply our denominator by to get to 100. If you don't have that, then you probably are going to be better off doing it this way, where you convert your fraction into a decimal and then into a percentage. Okay, for the next one, we're going to look at 7/8. So again, if your denominator does not multiply by a whole number to give you 100, it's probably easier just to do a division, right? It's probably easier just to say, okay, what is 7 divided by 8? Well, I'll put a decimal point here and bring it up into the answer. Put a 0 here. 8 is not going to go into 7, but it will go into 70. Well, I know 9 times 8 is 72. That's too big, so it's going to have to be 8. 8 times 8 is 64. Subtract, you get 6. Bring a 0 down. 8 is going to go into 60. 7 times 8 is 56. Subtracting, you get 4. And I know that I put another 0 here and bring this down. 8 is going to go into 45 times. 5 times 8 is exactly 40. Subtract here and get 0. So we've got 0.875. So 7/8 is 0.875. And then, of course, as a percentage, we just move this 2 places to the right. So that decimal point is going to go after the 7 and put our percentage symbol in. So 7/8 is equal to 0.875 in decimal form. And then it's equal to 87.5% when we think about it as a percentage. Now, let's say that you attempted to do it the other way. Let's say you think about just multiplying the denominator by some number so that your denominator would be 100. And of course, you have to match that in the numerator to make it legal. Well, 8 does not multiply by a whole number to get to 100, right? If you divide 100 by 8, you're going to get 12.5. So you would have to start out by doing that division. You'd have to say, okay, 100 divided by 8, you get 12.5. That's going to require you to do a little bit of work. It's not a long, drawn-out process, but you would have already gotten this number by the time you do that. That's why this is going to be a little bit slower. And then I have to multiply by 12.5 up here too. Now I know that 8 times 12.5 is 100 because I just did that division, right? And I didn't go through it on the screen because it's kind of tedious, but if you had done it on a scratch sheet, you would have already done it. You'd know that 8 times 12.5 is 100. But you still wouldn't know what 7 times 12.5 is. So you'd have to do another multiplication that has decimals involved. So in a way here, it's a little bit more drawn out if, again, the denominator for the fraction does not multiply by a whole number to give you 100. It's just faster to just do it this way. Divide 7 by 8, get 0.875, then convert it into a percentage as 87.5%. Now, if we wanted to, we can go through and say, okay, what is 12.5 times 7? Well, I'm going to kind of skip over doing that on scratch paper. We should be able to tell from this, provided I got the right answer, that it's 87.5, right? It would be 87.5 parts out of 100. So then my percentage, again, is the numerator, 87.5. Follow that with a percentage symbol, so 87.5%. So again, two different ways to get the same result. I just personally feel that it's quicker to do it the first way whenever we run into a scenario where the denominator does not multiply by a whole number to give you 100. All right, let's take a look at one more. We have 5 halves here. And in this particular case, 2 times 50 gives us 100. So it's probably going to be quicker for us just to say, okay, multiply the numerator and denominator here by 50. And what we're going to end up with is 250 over 100, or as a percentage, 250%. Now, again, the other way would work just fine. It's just not as fast because I can multiply the denominator here by a whole number to get to 100. So in this case, I would do what? 5 divided by 2. 2 goes into 5 twice. 2 times 2 is 4. Subtracting, get 1. Put my decimal point and bring it up into the answer to continue. Bring down the 0. 2 goes into 10 5 times. 5 times 2 is 10. Subtracting, get 0. So I have 2.5. 2.5. So 5 halves is equal to 2.5 as a decimal. And then move that 2 places to the right. You'd have 250, right? This would go 1, 2 places to the right. Put your percentage symbol in. And again, you get 250%. Hello and welcome to Pre-Algebra Test Section 4 on percents. All right, so we want to convert each to a decimal. And we're going to start out with 0.67%. So basically what we're doing is we're just going to reverse the procedure that took a decimal and put it as a percentage. So recall, to take a decimal and put it as a percentage, you move your decimal point 2 places to the right and you add a percent symbol. Well, now we're going to be moving the decimal point 2 places to the left and deleting the percent symbol. So let's rewrite this. 0.67%. I'm going to delete this. I don't need it. And I'm going to move this 2 places to the left. So 1. And let me kind of scooch this over so I have enough room. I'll put a 0 in there, and then let me continue. So then 2 places to the left. Let me kind of erase all this. And what I'll end up with is 0.0067. Right? So that's as a decimal. So 0.67% is equal to 0.0067. All right, for the next one, we have 32%. So let's write this as 32%. Again, we're going to delete this percent symbol. We don't need it. And our decimal point's going to get moved 2 places to the left. So remember, when you have a whole number like 32, although you don't visibly see a decimal point, one exists at the end of the number. So after the 2, you have a decimal point. And you move it 2 places to the left, so 1 and then 2. And so let's erase all of this. And so 32% is equal to 0.32. All right, for the last problem, we have 0.1507%. So let's write this, 0.1507%. And again, I'm going to delete this percent symbol, and I'm going to move this decimal point 1, put in a 0, and then 2 places to the left. So let's erase all this, and we can say that 0.1507% is equal to 0.001507. Hello and welcome to Pre-Algebra Test Section 5 on percents. All right, so we want to convert each to a decimal, and we're going to start out with 5.26%. So basically what we're going to be doing is reversing our procedure for taking a decimal and turning it into a percentage. Right? When we took a decimal to a percentage, we move our decimal point 2 places to the right, and we put a percentage symbol at the end. So to reverse that, we move the decimal point 2 places to the left, and we delete the percentage symbol. So I don't even need the percentage symbol anymore. I'm just going to write 5.26, and let me make that 5 a little better. Part of it was cut off. And all I need to do now is just move the decimal point 2 places to the left. So 1, and I'll put a 0 in here, and then 2 places to the left. So that's where my decimal point's going to go. And so 5.26% is equal to 0.0526. All right, now we have 0.00034%. So I don't need this percentage symbol anymore. Let's just copy the rest of this. So 0.00034. And I need to scooch this over just a little bit. So this is going to go 2 places to the left. So I'm going to go 1, and then let me put another 0 in, 2 places to the left. So I'll put my decimal point there. And so 0.00034% is equal to 0.0000034. All right, for the last one, we have 724%. So I'm going to write 724. Again, I don't need the percentage symbol anymore. So when we have a whole number, we don't have a visible decimal point, but we need to know that it exists at the end of the number. So after the 4 is a decimal point, right? We can write that in there. And then we can move it 2 places to the left. So 1, 2 places to the left. That's going to go right there. So we'd end up with 7.24. So 724% is equal to 7.24. Hello and welcome to Pre-Algebra Practice Set number 46. In this video, we're going to look at some additional practice problems for our lesson on finding the mean, median, and mode for a group of numbers. All right, so we want to find the mean, median, and mode for each. And we're going to begin today with -3, 15, 7, 21, 7, 2, and 21. So let's start out with finding the mean. And a lot of you will know this as finding the average. To find the mean or to find the average, basically what you want to do is sum the numbers. So in this case, I would just take all of the positive numbers, because I have one negative over here, and add them together. So let's do 21, and we have another 21, and then we have 15, and then we have 7, and then another 7, and then 2. So let's find this sum real quick. So 1 plus 1 is 2, plus 5 is 7, plus 7 again is 14, plus another 7 is 21, plus 2 is 23. Put a 3 down, carry the 2. 2 plus 2 is 4, plus 2 is 6, plus 1 is 7. So that's going to give me 73. So I have 73, and I want to add -3 to that. So this is very easy to do. So 73 plus negative 3 is the same thing as 73 minus 3. It's 70. Now we have our sum for this group of numbers. So let me just write that the sum is 70. So once I have the sum, all I need to do is divide by the number of numbers, and that will give me the average, or again, the mean. So 1, 2, 3, 4, 5, 6, 7. There are 7 numbers. So we would take the sum, which is 70, and divide it by 7, the number of numbers, and that would give us 10. So 10 is going to be our average, or again, our mean. So let's write that. The mean is 10. Now the next one we want to look at is the median. Now the median is found by arranging the numbers from smallest to largest. So the smallest number we have is negative 3. And then the next smallest is 2, followed by 7, and we have 2 of those. Then we have 15, and then we have 2 21s. Now once you've arranged your numbers in the group from smallest to largest, the median is the middle number. Now when your group of numbers is an odd number, like in this case we have 1, 2, 3, 4, 5, 6, 7 numbers. 7 is an odd number. So in this scenario, it's a bit easier because you have a middle number, right? This number right here is in the middle, so it's the median. And we know it's in the middle because there's the same number of numbers to the left of it as there are to the right of it. I have 1, 2, 3 numbers, and then 1, 2, 3 numbers. So the middle number is that 7, and that is the median. So let's write that this is the median. And then if you have an even number of numbers, it's a little bit more complicated. Basically, you're just going to average the 2 numbers in the middle. Okay, the last thing we want to do is find the mode. Now, the mode is the number that occurs most frequently in your group. So what are we looking at? We have negative 3, 15, 7, and then 21, 7 again, 2, and 21. So the numbers that occur most often are 7 and 21. Now, you can see that each occurs twice, and every other number only occurs once. You can have more than one mode. So in this case, we have 2 modes. So I'm going to put that our modes would be 7 and 21. All right, let's take a look at another one. We have 153, 18, 75, negative 1, 18, and 32. So we're going to start out by finding the mean again. So what is the mean? Again, just sum the numbers. So I have a negative involved. Sum everything that's not negative. So what is 153, 18, 75, 18, and 32? Let's add all that up. So 3 plus 8 is 11, plus 5 is 16, plus 8 is 24, plus 2 is 26. So put a 6 down, carry the 2. 2 plus 5 is 7, plus 1 is 8, plus 7 is 15, plus 1 is 16, plus 3 is 19. 9 down, carry the 1. 1 plus 1 is 2. So you have 296 as your sum. You're going to add that to negative 1. You're going to add that to negative 1 and get 295. And then just divide by the number of numbers you have. So you have 1, 2, 3, 4, 5, 6 numbers. So what is 295 divided by 6? 295 divided by 6. 6 does not go into 2. It'll go into 29 4 times. 4 times 6 is 24. Subtract here and you'll get 5. Bring down this 5. 6 goes into 55 9 times. 9 times 6 is 54. Subtracting you get 1. Let's continue our division by putting a decimal point and bringing it up into the answer. And we'll put a 0 here and bring that down. 6 is going to go into 10 only once. 1 times 6 is 6. Subtracting you get 4. Put a 0, bring it down. You'd have 40. 6 goes into 40 6 times. 6 times 6 is 36. Subtracting you get 4. So at this point you can stop because you just had a 4 there and it became 40 when you brought down a 0. Now if I bring down another 0, I'm just going to have 40 again. So this is a repeating decimal, right? This 6 is going to repeat forever and ever and ever. So we can say it's 49.16 with a horizontal bar over the 6 to say that will repeat forever. So this is 49.16 with a horizontal bar over the 6. So that's our mean, 49.16, again with a horizontal bar over the 6. All right, what about the median? What about the median? Again, arrange the numbers from smallest to largest. So -1 is the smallest. Then next we would look at 18, and there's 2 of those. Then we'd have 32, then 75, then 153. So now I'm looking for the middle number, and that's my median. The problem is here I have an even number of numbers. I have 1, 2, 3, 4, 5, 6 numbers. There is no exact middle number here because we have an even number. If I choose 18 here, that's kind of close to the middle. Well, I have 2 numbers to the left, but 3 numbers to the right, so that can't be the middle. Or if I choose 32, that also looks like it's close to the middle, but I have the same problem. I have 3 numbers to the left and 2 numbers to the right. So what we're going to do is we're going to take these 2 middle numbers and we're going to find the average, or find the mean. So what is the average of 18 and 32? Well, we would find the sum first. What is 18 plus 32? 18 plus 32. 8 plus 2 is 10. 0 down, carry the 1. 1 plus 1 is 2, plus 3 is 5. So that's 50. Now I just divide by the number of numbers. So the number of numbers I'm working with here, remember I'm just working with these 2 numbers in the middle, is 2. So 50 divided by 2 is 25, so the median is 25. Okay, so again, if you're looking for the median and you have an even number of numbers, it's a little bit more tedious, right? You got to take the average of the 2 middle numbers. So we sum the 2 middle numbers, 18 and 32. We got 50. Then we divide it by the number of numbers, which is 2, right? We're working with 2 numbers there. And 50 divided by 2 is 25, so that's our median. All right, so what's the mode? That's the next one we're looking at. What's the mode? So that's the number that occurs most often. So if I look in this, I see that I have 18. I have 18 that occurs once and then twice, and everything else only occurs once. So your mode is going to be 18. Hello and welcome to Pre-Algebra Test Section 1 on finding the mean, median, and mode. All right, so we want to find the mean. And remember, this is also known as finding the average. So what we do, we take our numbers in the group. So we have 34, -7, 21, and 8. And we find the sum, right? So we just add them to begin. So since we have a negative value involved, let's add the positive numbers first. So 34, 21, and 8. 4 plus 1 is 5. 5 plus 8 is 13. Put a 3 down, carry the 1. 1 plus 3 is 4, plus 2 is 6. So that result is 63. So now what I need to do is take 63 and add it to -7. So what is 63 plus -7? Well, I know that the absolute value of 63 is larger than the absolute value of -7. So it would be positive, and then I would just do 63 minus 7. So 63 minus 7. Borrow from the 6, this will be 5. This will be 13. 13 minus 7 is 6. Bring down the 5, I'd get 56. So the sum for the group of numbers here would be 56. The sum is 56. Now, the next thing we want to do is just count the number of numbers in the group. So we have 1, 2, 3, 4. And then we would divide the sum by the number of numbers. So what is 56 divided by 4? 56 divided by 4. That's going to be 14. So this equals 14. And this is your mean. This is your mean, or again, your average. All right, let's take a look at another one. We have 5, 14, 25, -11, -20, and 47. So because I have some negatives involved, I'm going to add the positive numbers first. So 5, 14, 25, and 47. So 47, 25, 14, and then 5. 7 plus 5 is 12, plus 4 is 16, plus 5 is 21. Put a 1 down, carry the 2. 2 plus 4 is 6, plus 2 is 8, plus 1 is 9. So that's 91. So then 91 plus, I have a -11 and a -20. Negative plus negative is negative, and then 11 plus 20 is 31. So 91 plus -31. Now I can almost do this in my head. Now if I have a positive 91 and I'm adding a -31, it's the same thing as if I had 91 minus 31. So that's just 60, right? Kind of you can mentally do that as 1 minus 1 is 0, 9 minus 3 is 6, right? Very, very easy to do. Now, I have my sum, and let me just write that that's the sum. The sum is 60. Now I just need to divide 60 by the number of numbers in the group. So 1, 2, 3, 4, 5, 6. So what is 60 divided by 6? That's another easy one to do in your head. That's going to be 10. And so 10 is going to be our mean, or again, you can call that the average. Hello and welcome to Pre-Algebra Test Section 2 on finding the mean, median, and mode for a group of numbers. All right, so again, we want to just find the mean here. And another word to say find the mean is find the average, right? You might be more familiar with that. So to find the average or to find the mean for a group of numbers, you're first going to sum the numbers. So we have 31, negative 72, 100, 512, and negative 10. So to find the sum here, we have some negatives involved. So we want to add our positive values first. So that's 512, 100, and then 31. So 2 plus 0 plus 1 is 3. 1 plus 0 plus 3 is 4. 5 plus 1 is 6. So the positive values here add up to 643. Your negative values here, negative 72 and negative 10, would give you negative 82. So what is 643? What is 643 plus negative 82? Well, of course, the sign's going to be positive, right? 643 has a much larger absolute value. And you're going to subtract the larger absolute value minus the smaller. So essentially, you just have the problem 643 minus 82. So I'm going to start out by doing 3 minus 2. 3 minus 2 is 1. And then I need to borrow here. This will become 5. This will become 14. 14 minus 8 is 6. Bring down the 5. So 561 is the sum, right? That's the sum for this group of numbers. So I'm just going to write here that the sum is 561. All right, now the next step is to divide by the number of numbers in the group. So we have 1, 2, 3, 4, 5 numbers in the group. So I would say, what is 561 divided by 5? And of course, I'm going to do that using a long division. So let's scroll down and get a little room. 561 divided by 5 here. 5 goes into 5 once. 1 times 5 is 5. Subtracting, you get 0. Bring down the 6. 5 is going to go into 6 once. 1 times 5 is 5. Subtracting, get 1. Bring down the 1. 5 goes into 11 twice. 2 times 5 is 10. Subtracting, get 1. To continue, I can put a decimal point and bring that up into the answer. Put a 0 here and bring that down. 5 goes into 10 exactly twice. 2 times 5 is 10. Subtracting, get 0. All right, so we have 112.2 as our answer. So let's go back up to the top, and we'll write that this is 112.2, and this is our mean, right? This is our mean or average. Sum the numbers in the group, then once you have that result, go ahead and divide it by the number of numbers in the group, and that gives you your mean or, again, your average. All right, let's take a look at one more problem. We have 71, 80, 83, 90, 51, and negative 300. So again, if you have a negative involved, just kind of leave that off to the side. We're going to find the sum for 71, 80, 83, 90, and 51. 1 plus 0 is 1, plus 3 is 4, plus 0 is still 4, plus 1 is 5. 7 plus 8 is 15, plus 8 again is 23, plus 9 is 32, plus 5 is 37. So you're going to get 375 there. And now I'm going to add that to negative 300. So that's pretty easy to do even in your head. So if I had 375 plus negative 300, basically I just have the problem 375 minus 300. That's just going to give me 75, right? Very, very simple to do that in your head. Now, once I have 75, I'm just going to divide that by the number of numbers, right? Because that's the sum. So we'll write out real quick that the sum is 75. And we have 1, 2, 3, 4, 5, 6 numbers. So what is 75 divided by 6? 75 divided by 6 is 12.5. And again, this is your mean, or you can say this is your average, 12.5. Hello and welcome to Pre-Algebra Test Section 3 on finding the mean, median, and mode for a group of numbers. All right, so we want to find the median here. And we're going to start out with this group of numbers 88, 20, negative 4, 29, 17, and 103. So to find the median, what we want to do is arrange the numbers from smallest to largest. So the smallest number here is negative 4. So negative 4 And then kind of the next smallest would be 17. And then followed by that is 20, then 29, then 88, then 103. Now, in the scenario where you have an odd number of numbers, this is a very, very easy process. With an odd number of numbers, you just choose the number that's in the middle once you've arranged the numbers from smallest to largest. In this case, we don't have that. We have 1, 2, 3, 4, 5, 6 numbers, so there really is no middle. So what we do in this scenario where we have an even number of numbers is we just take the average of the two numbers that are in the middle. So if I take the average of these two numbers, I would have two numbers that come before and two numbers that come after. Right? I'm just considering this the middle now. So what I want to do is find the average of 20 and 29. And to do that, I sum the numbers. 20 plus 29 is 49. And then I divide by the number of numbers, which in this case we're working with two numbers. So 49 divided by 2. So what is 49 divided by 2? 2 goes into 4 twice. 2 times 2 is 4. Subtracting, get 0, bring down the 9. 2 goes into 9 4 times. 4 times 2 is 8. Subtract here and get 1. I'll put a decimal point here and bring it up into the answer. Put a 0 here and bring it down. 2 goes into 10 5 times. 5 times 2 is 10. Subtracting, get 0. So 24.5. 24.5. And that's going to be our answer, right? That's going to be our median. So I'll just say that the median is 24.5. And again, when you have this scenario where you have an even number of numbers, it's just the average of the two middle numbers. All right, let's take a look at another one. We have 14, 18, 150, 121, negative 11, negative 20, and 54. So again, let's arrange these numbers from smallest to largest. So negative 20 is the smallest. Negative 11 is the next smallest. Then let's see, we'd have 14, 18, 54, 121, and then 150. And I have 1, 2, 3, 4, 5, 6, 7 numbers. So we have an odd number of numbers. So this is very, very simple. The median is just the middle number, and that's 18. Right? You can see you have 1, 2, 3 numbers that come before it, and 1, 2, 3 numbers that come after it. So it's perfectly in the middle. So 18 is our median. Hello and welcome to Pre-Algebra Test Section 4 on finding the mean, median, and mode for a group of numbers. All right, so we want to find the median. And so for our group of numbers, we have 22, 23, 28, 29, 71, and 15. And to find the median, what we want to do is arrange the numbers from smallest to largest. So in this particular case, all I need to do is take this 15 and put it at the front. So I would have 15, 22, 23, 28, 29, and then 71. Once I've done that, there's kind of two different scenarios. If you have an odd number of numbers, basically your median is just the middle number. If you have an even number of numbers, it's the average of the two middle numbers. So what I mean by that, in this case, we have an even number of numbers. We have 1, 2, 3, 4, 5, 6 numbers. So there's not really a middle number. If I look at 23, there's two numbers before it, but three numbers after it. If I look at 28, there's three numbers before it, but two numbers after it. So nothing's really directly in the middle. So what we do is we average these two middle numbers, right? If you think about these two combined together, right? If we think about those as the two middle numbers, there's two numbers that come before that and two numbers that come after, right? So that's what we're going to consider here. And basically, we just want to take the average of these two numbers. So to take the average, we would sum 23 and 28. So 23 plus 28. 3 plus 8 is 11. 1 down, carry the 1. 1 plus 2 is 3, plus 2 is 5. So 51. And then I would divide by the number of numbers, which in this case we're working with two numbers, so we're dividing by 2. So what is 51 divided by 2? 2 goes into 5 twice. 2 times 2 is 4. Subtract and get 1. Bring down the 1. 2 goes into 11 5 times. 5 times 2 is 10. Subtract and get 1. Now I'm going to continue my division. Go ahead and put a decimal point here and bring it up. Put a 0 here and bring it down. 2 goes into 10 5 times. 5 times 2 is 10. Subtract and get 0. So 25.5. 25.5. So that's going to be our median. And again, when you have an even number of numbers, it's just the average of the two middle numbers. All right, let's take a look at another one. We have negative 2, negative 7, 14, and negative 9. So again, I want to arrange the numbers from smallest to largest. The smallest number here is -9. Right? The smallest number when you have negatives involved is always the biggest negative. -9 is a bigger negative than -7 or -2, so it's the smallest number. Then the next biggest negative is -7, so that's the next smallest. Then -2, and then of course +14 is the largest. Now again, we have the scenario where we have an even number of numbers. I have 1, 2, 3, 4 numbers. So I'm just going to take the middle two numbers and average them. What is the average of -7 and -2? Well, -7 plus -2, negative plus negative is negative, and then 7 plus 2 is 9. So you'd have -7 plus -2 is -9, and then we would divide -9 by the number of numbers, which is 2. So -9 divided by 2 is what? Well, we know it's negative. We know it's negative. And then let's just do 9 divided by 2. 2 goes into 9 4 times. 4 times 2 is 8. Subtract and get 1. Put a decimal point here, bring it up into the answer. Put a 0 and bring it down. 2 goes into 10 5 times. 5 times 2 is 10. Subtract and get 0. So 4.5. So this is -4.5. And that's going to be my median, right? Because that's the average of the two middle numbers. So the median for -2, -7, 14, and -9 is going to be -4.5. Hello and welcome to Pre-Algebra Test Section 5 on finding the mean, median, and mode. All right, so we want to find the mode. And remember, to find the mode is very, very, very easy. You're just looking for the number that occurs most often in your group of numbers. So we have 2, -4, 7, 3, 2, 5, 7, 2, 18. So you just kind of eyeball it and see, okay, well, I know that 2 is here, here, and here. So I have 3 occurrences. And then with a different highlighter, I can see that 7 occurs here and here. Everything else only occurs once. Now 2 occurs 3 times, 7 occurs twice. So the number that occurs most often is 2. So 2 is the mode. And it's just that simple. All right, for the next problem, we have 24, 17, 21, -7, 17, 12, 24, and 13. So let's just take a look at what occurs more than once. So we have 24 that occurs here and here. And we have 17 that occurs here and here. And everything else just occurs once. So 24 occurs twice, and so does 17. So in this case, we have 2 modes. So we would say there are 2 modes. 17 and 24, right? They each occur twice, whereas every other number only occurs once. Hello and welcome to Pre-Algebra Practice Set number 47. In this video, we're going to look at some additional practice problems for our lesson on converting between US units of measurement. So let's start out by just taking a look at some of the common relationships you're going to see between units. So for length, I have that 12 inches equals 1 foot, 3 feet equals 1 yard, 5,280 feet equals 1 mile. For weight, I have that 16 ounces equals 1 pound, 2,000 pounds equals 1 ton. For volume, I have that 2 cups equals 1 pint, 2 pints equals 1 quart, and 4 quarts equals 1 gallon. And then for time, I have that 60 seconds equals 1 minute, 60 minutes equals 1 hour, 24 hours equals 1 day, and 7 days equals 1 week. Okay, so we just want to perform each conversion. And we're going to start out with an easy one. We have 25 feet, 2 yards. So the first thing we want to do is we want to identify the relationship between the units that we're going to be working with. We have feet and we have yards. So earlier I showed you that 3 feet is equal to 1 yard. Okay, 3 feet is equal to 1 yard. So I'm going to write that here real quick. 3 feet is equal to 1 yard. Now the next thing we're going to do is we're going to set up a unit fraction. Now the unit fraction shows the relationship between the two units, and it has a value of 1, right? Just like if I had 17 over 17, right? That equals 1. Even though it's a complicated form of 1, you still follow the rule that if you multiply something by 1, it's going to remain unchanged, right? It might look different, but it remains unchanged. All right, so to set up the unit fraction, we always want to put the units that we want to end up with in our numerator. In this case, we're going from feet to yards. So when I write the relationship here, I want to put 1 yard in the numerator, And I want to put 3 feet in the denominator. And I'm just going to multiply this guy right here by my starting value, which was 25 feet. So we'll have 25 feet times 1 yard over 3 feet. Okay, so the units here that we don't want anymore are going to cancel themselves out. So this feet here will cancel with this feet here. And what I'm going to end up with is basically 25 times 1 over 3. Now, what I'm left with here in terms of units will be yards. And I know it says yard right there, but you can go ahead and just say yards. Yards. We just need to do the calculation of 25 times 1/3, which is basically 25 divided by 3. So 25 divided by 3. 3 does not go into 2. It will go into 25 8 times. 8 times 3 is 24. If we subtract it, we get 1. Let's put a decimal point here so we can continue our division. We'll put a 0 here and bring it down. 3 goes into 10 3 times. 3 times 3 is 9. If I subtract, I get 1. So you see that you have an infinitely repeating digit there, right? You have a repeating decimal. So you would have 8.3333333 where that 3 continues forever. And so let's go back up to the top. And we have 2 choices basically. So as a fraction, we could say we have 25 over 3. We have that number of yards. Or using a decimal, we can say 8.3 with a horizontal bar over the 3 to say that that 3 continues forever, that many yards. Either way, both answers would be acceptable. Okay, what about 3.5 pounds to ounces? So what's the relationship between pounds and ounces? So I have here under weight, 16 ounces equals 1 pound. So again, 16 ounces is equal to 1 pound. So once we've identified the relationship between the 2 units we're working with, again, we're going to set up a unit fraction. Now we always want to put the units we want to end up with in our numerator. So we're going from pounds to ounces. So we're going to put ounces in our numerator. So we'll have 16 ounces over 1 pound. Okay, we're multiplying this by what we started with, which is 3.5 pounds. 3.5 pounds. And let's see what we get. We know that the units that we don't want will cancel. So pounds will cancel with pounds. I'm just going to be left with ounces for the units. So let's go ahead and write that down here, ounces. And basically all I have is 3.5 times 16. So 3.5 times 16. And again, you can just ignore that decimal point for now. 6 times 5 is 30. Put a 0 down, carry the 3. 6 times 3 is 18. Plus 3 is going to be 21. I'll go ahead and erase this. Now we have 1 times 35, and that's 35. Bring down the 0. 1 plus 5 is 6. 2 plus 3 is 5. So I've got 560, but notice how I have a decimal point there. So I have 1 decimal place between these 2 factors. So that means this would go 1 place to the left, and I just have the number 56. So 3.5 pounds would be equal to 56 ounces. All right, let's take a look at another one. We have 42 minutes to seconds. So what's the relationship between minutes and seconds? There are 60 seconds in 1 minute. So 60 seconds is equal to 1 minute. So 60 seconds is equal to, again, 1 minute. All right, so we want to end up with seconds. So when I set up the unit fraction, I'm going to put 60 seconds in the numerator, because that's what I want to end up with in terms of seconds. I'm going to put 1 minute in the denominator. I'm just going to multiply it by the starting value, which is 42 minutes. And our units that we no longer want are going to cancel, minutes with minute. And I just basically multiply 42 times 60. Now, the quick way to do that, because 60 has a trailing 0, is to say, what is 42 times 6? What is 42 times 6? 6 times 2 is 12. 2 down, carry the 1. 6 times 4 is 24, plus 1 is 25. So I've got 252, and then I would just attach a trailing 0 to that. So this would be 252, put a 0 behind it, so it's 2,520, and then seconds. Okay, so 42 minutes is 2,520 seconds. All right, let's look at one that's a little bit more tedious. And in this scenario, we're going to do multiple conversions in one shot. So we have 3 days to seconds. So we don't know the relationship between days and seconds, and you can figure it out, but in most cases you're going to know the relationship between seconds and minutes, minutes and hours, hours and days. So what you'll do is, let's start out by saying, we know there's 60 seconds in 1 minute. We know there's 60 minutes in 1 hour. And we know there's 24 hours in 1 day. So I'm starting with 3 days, and I want to go to seconds. How many seconds are in 3 days? Well, the first thing I would do to get to seconds starting from days, I would convert it to hours. So my unit fraction here will have hours in the numerator, so 24 hours, and it'll have 1 day in the denominator. This will put our relationship in terms of hours. Now the next thing I'm going to do is I'm going to get it in terms of minutes. So this relationship between hours and minutes, 60 minutes equals 1 hour. The unit fraction here, I'll have 60 minutes in the numerator. I'll have 1 hour in the denominator. So this puts it in terms of minutes. Now the last thing I want to do is put it in terms of seconds. So I'm going from minutes to seconds. So 1 minute is 60 seconds. So I'm putting 60 seconds in the numerator, and I'm putting 1 minute in my denominator. Okay, so this will finally put it in terms of seconds. And you can see you're just doing multiple conversions in one shot. And nothing more complicated about it. Sometimes the arithmetic is kind of challenging, but if you're allowed to use a calculator, really once you've set it up, you've done all the work. So you can see that everything you don't want is going to cancel. Days will cancel with day, hours will cancel with hour, minutes will cancel with minute, and you're just left with seconds, which is what you want. So this will be something, and then you'll have seconds. All right, so let's do some multiplication here. Every denominator is 1, so you can just look at 3 times 24 times 60 times 60. So let's do 3 times 24 first. 24 times 3. 3 times 4 is 12. 2 down, carry the 1. 3 times 2 is 6, plus 1 is 7. So that's 72. And then I need to multiply by 60, and then by 60 again. I can save myself some time because if I have 72 times 60 times 60, there's 2 trailing zeros here, right? 1 there and 1 there. So what I can do is 72 times 6 times 6, and whatever I get, just attach 2 trailing zeros to the end of that. 6 times 6 is 36. So basically I just need to do 72 times 36, and then whatever I get, just attach 2 trailing zeros. So let's do that real fast. So 6 times 2 is 12. 2 down, carry the 1. 6 times 7 is 42, plus 1 is 43. 3 times 2 is 6. And then 3 times 7 is 21. Let's add here. Bring down the 2. 3 plus 6 is 9. 4 plus 1 is 5. Bring down the 2. So 2,592. And then attach 2 trailing zeros. So 1, 2. You get 259,200. So we'll come back up to the top and say this is 259,200 seconds, right? Again, 3 days was converted to hours, then minutes, then finally seconds. And we got an answer of 259,200 seconds. All right, let's take a look at one final problem. And again, it's going to be one where we do multiple conversions in one shot. So we want to go from 4 tons to ounces. So if you look at the relationships I have here for weight, I have 16 ounces equals 1 pound and 2,000 pounds equals 1 ton. But I don't have anything from tons to ounces, right? I don't have that relationship. You could figure that relationship out if you wanted to, but if you don't know it, you're either going to have to figure out that relationship or do multiple conversions. All right, so 16 ounces is equal to 1 pound, and then 2,000 pounds is equal to 1 ton. Again, we're starting with 4 tons. 4 tons. And the first thing we want to do is go from tons to pounds, right? Because I'm not going from tons to ounces. I don't know that relationship. So from tons to pounds, what I would do is I would multiply by 2,000 pounds over 1 ton. My unit fraction will have a numerator with the units I want to end up with. Next, I'm going to convert to ounces. I'm going to go from pounds, right? This puts it in terms of pounds. So we see 16 ounces equal to 1 pound. So I want to end up with ounces. So ounces goes in the numerator. So 16 ounces over 1 pound. And this will give me what I want, which is in terms of ounces. So you can see everything you don't want cancels. So tons cancels with ton, pounds cancels with pound, and you're left with ounces. Let's put this over here. We'll have ounces. And now we just do some basic arithmetic. We have 4 times 2,000 times 16, right? 4 times 2,000 times 16. And that's pretty easy to do. You could do 16 times 4. 4 times 6 is going to be 24. 4 down, carry the 2. 4 times 1 is 4, plus 2 is 6, so that's 64. Now to multiply by 2,000, I just need to multiply by 2 and attach 3 trailing zeros. So 64 times 2. Well, a lot of you already know it's 128, but 2 times 4 is 8, then 2 times 6 is 12. So that's 128, and again, we're just going to attach 3 trailing zeros. So we're just going to say that this is 128,000, right? I'm putting 3 zeros behind that 8 ounces. So 4 tons was converted to pounds, then ounces, and we ended up with 128,000 ounces. Hello and welcome to Pre-Algebra Test Section 1 on converting between US units of measurement. Okay, so we just want to perform each conversion, and we're going to start out with 32 hours to minutes. So hopefully you watched the lesson. Even if you didn't, you can pick this up from a few practice problems. The first thing you always want to do is identify the relationship between the units. In some cases, if you haven't memorized them, at this point you have to stop and go back and look things up. But for hours to minutes, we deal with time so frequently, most of us will know that 1 hour is equal to 60 minutes. 60 minutes. Once you know the relationship between the units, you're going to set up something called a unit fraction. Now, for the unit fraction, you have to be specific. You want to put the units that you want to end up with in the numerator of the fraction. And the purpose of that, as you'll see, is that so the units that you don't want are going to cancel themselves out. So in this case, we're going from hours to minutes. So we want to end up with something in terms of minutes. So when we look at this relationship here, we want to put 60 minutes in our numerator, because again, we want to end up with minutes. And we want to put 1 hour in the denominator, because we don't want hours anymore. We don't want it in that form. So I'm going to multiply this by our starting value, which is 32 hours. 32 hours. And remember, 60 minutes over 1 hour is just equal to 1, right? They're equal to each other, 1 hour and 60 minutes. So just like when we work with fractions and we multiply by 6 over 6 or 17 over 17, we're multiplying by a complicated form of 1. And so we're not changing the value, we're just changing what it looks like. So let's do our conversion. These units here will cancel. And I know some of you will say, well, this is plural and this is singular. That doesn't matter. You have hours over hour, same units, those cancel out. Next, I have 32 times 60 over 1, which is the same thing as 32 times 60. And that's kind of easy to do. You can do 32 times 6, and put a trailing 0 at the end. 6 times 2 is 12. 2 down, carry the 1. 6 times 3 is 18, plus 1 is 19. So 1,920. Right, I had 192, put a trailing 0 at the end, 1,920. And then don't forget to write your units, which I don't know if I can fit them on that line. Let's bring that down here. 1,920. And then, of course, we have minutes. So 32 hours converted to minutes is 1,920 minutes. All right, let's take a look at another one. We have 330 feet to miles. And this is one that you might not remember, right? What is the relationship between feet and miles? But again, as you look these things up as you're practicing, you're going to memorize them. And then when you get to your test, if your teacher's not nice enough to give you a cheat sheet, you'll know most of these off the top of your head. The relationship between feet and miles, you have 5,280 feet is equal to 1 mile. Now, I want to end up with miles. That's what I wanted in terms of. So when I set up my unit fraction, I want 1 mile on top. Again, that's what I want to end up with. I want to end up with something in terms of miles. And I want 5,280 feet on the bottom, because I want to get rid of feet. I don't want that anymore. So then I have 330 feet then I'm going to multiply this by. And of course, the units I don't want are going to cancel out. This is going to cancel with this, and I'm just left with this as my unit. So now what I have is 330 times 1 over 5,280. So let's set that up as a division problem. So 330, and we're dividing that by 5,280. Of course, to do this, I have to put a decimal point here, bring that up into the answer, put a 0 here to start my division. 5,280 will not go into 3, will not go into 33, will not go into 330, and also will not go into 3,300. But again, these zeros out here to the left of the decimal point don't matter, so we can kind of skip that over. When we get to this 0 here, we have to put it. It's going to matter because after that 0, I'm going to have some non-zero values, and so that 0 is going to matter. If this ends up getting squished down to the left, it's going to change the value of the number, and I won't have the right answer. So I'm going to put that 5,280 does not go into 3,300. Put a 0 there. 0 times 5,280 is 0. Subtract. I'm going to just bring this whole number down, 3,300. And put a 0 here and bring that down. So how many times will 5,280 go into 33,000? Well, it's not going to be able to go in 7 times. It looks like the answer to that would be 6. Basically, you can kind of approximate that to 5,000 and multiply by 7 and you get 35,000. And you see that's too big already, right? Just with an approximation. So it has to be 6, right? It can't be 7. So what is 5,280 times 6? 6 times 0 is 0. 6 times 8 is 48. Put an 8 down, carry the 4. 6 times 2 is 12, plus 4 is 16. 6 down, carry the 1. 6 times 5 is 30, plus 1 is 31. So 31,680. So 31,680. Let's do our subtraction here. I don't need to borrow here. 0 minus 0 is just 0. I'll borrow here. This will be 2. This will be 10, then 9, then 10. 10 minus 8 is going to give me 2. 9 minus 6 is going to give me 3. 2 minus 1 is 1. So I've got 1,320. Let's put a 0 here and bring this down. So 13,200. So this is only going to go into this twice, right? Twice. 2 times 5,280. 2 times 0 is 0. 2 times 8 is 16. 6 down, carry the 1. 2 times 2 is 4, plus 1 is 5. 2 times 5 is 10. So 10,560. So 10,560. Let's subtract. 0 minus 0 is 0. And then I need to borrow here. This 2 will become 1. Then this will become 10. 10 minus 6 is 4. Borrow again. This will become 2. And this will become 11. 11 minus 5 is 6. 2 minus 0 is 2. So I get 2,640. Let's go back up to the top. We'll put a 0 here and bring that guy down. So now I have 26,400. And I have the divisor off the screen, but it's 5,280. So how many times will 5,280 go into 26,400? Well, let's think about that down here. We have 5,280 times what? Well, I know that 5 times 5,000 is 25,000. So let's check that 5 out. Let's see if that works out. 5 times 0 is 0. 5 times 8 is 40. 0 down, carry the 4. 5 times 2 is 10, plus 4 is 14. 4 down, carry the 1. 5 times 5 is 25, plus 1 is 26. So that works out perfectly, 26,400. So my answer here is going to be a 5. Again, 5 times 5,280 is going to give me 26,400. Subtract and get 0. So let me erase all this so that it's not in my way. And I'll just bring the answer up here. And we'll put equals. And of course I need to put the units behind it. And let me kind of write this on the next line down just so I can fit everything. So again, we started with 330 feet. And we convert that into miles as 0.0625 miles. Hello and welcome to Pre-Algebra Test Section 2 on converting between US units of measurement. All right, so we want to perform each conversion. And we're going to start out with 7 tons to pounds. So the first thing you need to know is the relationship between the units. And for some of the things you're going to know right away because you use it in everyday life, especially measurement in terms of time. But some of you won't know the relationship between tons and pounds, right? It's just something you have to learn through practice. So the relationship is that 2,000 pounds is equal to 1 ton. 1 ton. Now, once you have that relationship, you want to set up something known as a unit fraction. And basically what you want to do is you want to put the units that you want to end up with in the numerator and the units you don't want anymore in the denominator. And what's going to happen is the units you don't want are going to cancel themselves out. So because we're going from tons to pounds, I'm going to put pounds in the numerator. So I'm going to put 2,000 pounds over 1 ton. And just like when we work with fractions, remember if I had 7 over 7, the value was 1, right? 7 is the same as 7. So these two are equal. So when I put them as a fraction, the value is 1. So when I multiply by this complicated form of 1, I'm not changing the value, I'm just changing what it looks like. So I'm going to start out here again with 7 tons and multiply by the unit fraction. Once you've gotten to this point, everything else is just like multiplying with fractions. These units here that you don't want are going to cancel. Tons is going to cancel with ton. And you just basically have 7 times 2,000, right? And then the units after that would be pounds. 7 times 2,000 is easy because of these trailing zeros. You do 7 times 2. That's going to give you 14. And you put 1, 2, 3 trailing zeros behind it. So you'd have 14,000. And then don't forget your units. It's going to be pounds. So 7 tons is going to be equal to 14,000 pounds. All right, let's take a look at another one. We have 360 hours to days. So a lot of us do know the relationship between hours and days because, again, it's something we use all the time. So we know that 24 hours is equal to 1 day. So if I want to end up with days, right, if I want to go from hours to days, then my unit fraction will have days in the numerator, or 1 day in the numerator, and 24 hours in the denominator. So I'm just going to multiply 360 hours by this unit fraction here. And again, the units that we don't want will cancel out. Hours will cancel with hours. And I'm basically just left with 360 times 1 day over 24. Right? Just forget about this unit here for a second. And just think about it as 360 times 1 over 24. That's basically 360 divided by 24. Let's crank out that division. 24 will not go into 3. It will go into 36 once. 1 times 24 is 24. Subtract here and get 12. Bring down the 0. 24 will go into 120 5 times. 5 times 24 is 120. Subtract and get 0. So it's going to be 15. So this is going to be equal to 15. And then don't forget that unit. So 15 days. So again, 360 hours is going to be equal to 15 days. Hello and welcome to Pre-Algebra Test Section 3 on converting between US units of measurement. So we just want to perform each conversion, and we just have one problem to do because it's a little tedious. We have 126,720 inches to miles. So we're going to be doing multiple conversions here in one shot. And let me just kind of scroll up real quick, and we're going to look at the relationship between different units of length. So here I have two relationships we're going to use. 12 inches equals 1 foot, and 5,280 feet equals 1 mile. So again, 12 inches is equal to 1 foot. And then again, 5,280 feet is equal to 1 mile. Now, normally what we're going to do, if we just have one step in our conversion, we take our starting amount, which in this case is 126,720, and then the units are inches. We multiply that by a unit fraction where the units we want to end up with are in the numerator. So we're going to do that, but we're going to have to do it twice. So we're going to start out with inches, and instead of going straight to miles, we're going to convert to feet. So I'm going to multiply this by 1 foot over 12 inches. And what this is going to do, again, it's going to put it in terms of feet for me, because inches are going to cancel out. right? Those units will be gone, and I'm just left with this in terms of feet. Now I want to go from feet to miles. So I'm going to do one more multiplication here. And essentially what I'm going to do is I'm going to multiply by a unit fraction where I have miles in the numerator. In this case, it's singular, so just 1 mile. 1 mile over 5,280 feet. And of course, the units here will cancel out. I have foot, and then I have feet. And again, don't get too mixed up between your units being singular or plural. They just cancel out. So now what I'd be left with is miles, right? Miles. Everything else I'm working with is just numbers. So when I go to write my answer, I'm just going to put equals. And let me scroll down here. Again, when I go to write my answer, I'm just going to put that I have miles. And now I can just work with the numbers. So essentially I have 126,720. And that's basically going to be divided by the product of 12 times 5,280. So let's do that on a scratch sheet. Let's first multiply 12 times 5,280. 2 times 0 is 0. 2 times 8 is 16. 6 down, carry the 1. 2 times 2 is 4, plus 1 is 5. 2 times 5 is 10. Now 1 times anything is itself. But I just need to make sure that, again, I back my answer up because I'd start in the tens place here. So I'd put a 0, an 8, a 2, and then a 5. So let's add, bring down the 0. 6 plus 0 is 6. 5 plus 8 is 13. 3 down, carry the 1. 1 plus 0 is 1. Plus 2 is 3. Then 1 plus 5 is 6. So 63,360. I'm going to just erase everything else. Let's go back up to the top for a second and get that other number. So again, we had 126,720. And we're dividing that by the product of these two, which again, we have down here, 63,360. Let me kind of move this up a little bit. And we'll put this like this. Again, so 126,720. Now, these are pretty big numbers to work with, but if you kind of eyeball them, you'll notice that if you just estimate this first number here as 60,000, and you estimate this as 120,000, you can kind of see that this times 2 would give you this. So based on the way that problems are designed, you can kind of eyeball this and guess that the answer would be 2. So let's just multiply this, 63,360 by 2, and see what we get. We're probably going to get this. 2 times 0 is 0. 2 times 6 is 12. 2 down, carry the 1. 2 times 3 is going to be 6, plus 1 is 7. 2 times 3 is 6, and then 2 times 6 is 12. So 126,720 is what you get. And so for the division problem, 126,720 divided by 63,360, we get exactly 2. Right? So we'll go back up, and we know we can just write the answer as 2 miles. Let me kind of move this over a little bit. 2 miles. Okay? So again, 126,720 inches is going to be equal to 2 miles. Hello and welcome to Pre-Algebra Test Section 4 on converting between US units of measurement. All right, so we just want to perform each conversion. And we're just going to take a look at one problem here because this problem here is going to take us a little bit of time. We have to do multiple conversions in one shot. So we want to do 3,240 inches to yards. So we're going to go up to the top real quick and we're going to look at some common US units of measurement that involve length. So for length, I have 12 inches equals 1 foot and 3 feet equals 1 yard. So these are the two that we're going to work with here. So again, let's write that down. 12 inches. 12 inches is equal to 1 foot. And then 3 feet. 3 feet is equal to 1 yard. So because I want to go from inches to yards, and I don't know what the relationship is between inches and yards directly, I need to take inches and convert it to feet, and then go from feet to yards. So it's going to be a two-step process. So let's start out with what we have, which is 3,240 inches. And let's convert that into feet. So the way we do that is we set up a unit fraction where feet would be in the numerator. So here I have 12 inches is equal to 1 foot. So my unit fraction would be 1 foot over 12 inches. For the next part, I need to convert into yards because that's what I want to end up with. This puts it in terms of feet. And then I'm going to go from feet to yards. So my next unit fraction will have 1 yard in the numerator over 3 feet in the denominator. This is going to put it in terms of yards. You can see that what you don't want is going to cancel out. Inches will cancel with inches. Foot will cancel with feet. And I'm just left with that unit that I wanted to end up with, which in this case is the singular form where we say yard, but really we're looking at it in terms of yards. So I know in the end, I'm going to have yards down here. So I can go ahead and write that now. And I'm just looking at a basic problem with fractions. 3,240 times 1/12 times 1/3. So 3,240 divided by 36. So 36 will not go into 3 or 32. It will go into 324. Looks like 9 times. What's 9 times 36? 36 times 9. 9 times 6 is 54. 4 down, carry the 5. 9 times 3 is 27. Plus 5 is 32. So you get exactly 324. So 324. Subtract here, and you get 0. Bring down the 0. 36 does not go into 0, so we're going to put 0. 0 times 36 is 0. Subtract and get 0. So we get 90 there. So we're going to put 90 yards for our answer. So 3,240 inches is going to be equal to 90 yards. Hello and welcome to Pre-Algebra Test Section 5 on converting between US units of measurement. All right, so we just want to perform each conversion. And we're only going to look at one problem here because it's going to be one of those problems where we have to do multiple conversions in one shot. So we want to do 22.5 days to seconds. So again, if you don't know the relationship between days and seconds, you're going to have to break it down to a multi-step process. We know that 60 seconds equals 1 minute. We know that 60 minutes equals 1 hour. We know that 24 hours equals 1 day. So to go from days to seconds, essentially what I'm going to do is I'm going to start out with 22.5 days. And I'm going to multiply by a unit fraction where hours is going to be in my numerator. So 24 hours over 1 day. And why did I do that? Well, basically what I'm going to do is I'm going to take days, convert it to hours, then I'm going to take hours, convert it to minutes, and then I'm going to take minutes and convert it to seconds. So basically I'm going through it that way. Now, this puts it in terms of hours. Now, the next thing I want to do, as I mentioned, was put it in terms of minutes. So I would multiply again, and now I'm going to have minutes in my numerator, so 60 minutes over 1 hour. And I won't be able to fit all this on the screen, so I'm just going to scroll over a little bit. The last thing I want to do, since this puts it in terms of minutes, is multiply by, and you'll see all the way up here at the top, I have 60 seconds equals 1 minute. So multiply by 60 seconds over 1 minute. This will put it in terms of seconds, which is what I want. I just want you to see that the units here that you don't want are going to cancel. Days will cancel with day. Hours will cancel with hour. Minutes will cancel with minute. So now all I'm left with for my units is seconds. So I'm going to put equals something and then seconds. So let's think about this multiplication problem. All the denominators are 1. So essentially I just have to think about 22.5 times 24 times 60 times 60. Now I'm going to do 60 times 60 last because each has a trailing 0. So what is 22.5 times 24? So 22.5 times 24. And again, just ignore that decimal point. I'll just erase it for now. 4 times 5 is 20. 0 down, carry the 2. 4 times 2 is 8, plus 2 is 10. 0 down, carry the 1. 4 times 2 is 8, plus 1 is 9. So that's 900. And then we move to the left, so we start here. 2 times 5 is 10. 0 down, carry the 1. 2 times 2 is 4, plus 1 is 5. 2 times 2 is 4. So we add here, bring down the 0. 0 plus 0 is 0. 9 plus 5 is 14. 4 down, carry the 1. 1 plus 4 is 5. So 5,400. So again, our result was 5,400. But remember, we multiplied, and we had one decimal place between the two factors. So this decimal point would go one place to the left, and essentially I would just have 540. Now we need to multiply this by 60, and then times 60 again. Now we're in luck because we have trailing zeros here. And so what I'm going to do is I'm going to multiply 54 times 6. I'll take that result, multiply it by 6, and then I'll attach 3 trailing zeros to the answer. So 6 times 4 is 24. 4 down, carry the 2. 6 times 5 is 30, plus 2 is 32. So I've got 324. So let's multiply that by 6. 6 times 4 is 24. 4 down, carry the 2. 6 times 2 is 12, plus 2 is 14. 4 down, carry the 1. 6 times 3 is 18, plus 1 is 19. So I've got 1,944. And remember, you've got 3 trailing zeros between these factors. You got one there, there, and there. So I'm going to put 1, 2, 3 trailing zeros there. And I get 1,944,000. So let me kind of scoot this over. We have 1,944,000. And again, this was in terms of seconds. So we have that 22.5 days is equal to 1,944,000 seconds. Hello and welcome to Pre-Algebra Practice Set number 48. In this video, we're going to look at some additional practice problems for our lesson on converting between metric units. All right, so we just want to perform each conversion. And we're going to start out with 32 kilograms to decagrams. So I kind of showed you an easy method to do this in the lesson. Basically, what we're going to do is we're going to use a prefix chart to convert between our metric units. Now, the way this works is you identify the prefix in what you're starting with and what you're converting to. So the prefix for kilograms would be kilo, right? That's the part that comes before grams. And the prefix for decagrams would be deca. Now you find those on the prefix chart. So your prefix chart has kilo here, and it has deca here. And then you basically just match the movement and the direction from the prefix chart and the number where you're converting. So we have 32. Let's write that real quick. And I'm going from kilo to deca. So if I look at my prefix chart, I'm starting at kilo here, and I'm going 1, 2 places to the right to end up at deca. So all I need to do is take 32 and move my decimal point 2 places to the right. So I'm going to put 2 zeros behind the decimal point, and I'm going to go 1, 2 places to the right, and I'm going to end up with 3,200, and then what I'm converting to, decagrams. So decagrams. Let's take a look at another one. So we have 14 liters to milliliters. So again, we're looking at the prefixes to start. So liters is the basic unit. So that's right here. And then milliliters, we have milli, that comes before liters. That's right here. So I'm going to write my number down, which is 14. And I'm going from the basic unit, liters, to milliliters. So that means I'm going to go on the prefix chart 1, 2, 3 places to the right. And I just need to match that movement with my decimal point in this number. So I'm going to put a decimal point here. And I'm going to need to add 3 zeros behind the decimal point. So 1, 2, 3. And then I'll move this decimal point 1, 2, 3 places to the right. And that's going to give me the number 14,000. And then go ahead and write your units that you're converting to, which in this case is milliliters. So 14,000 milliliters. All right, for the next one, we have 1.97 hectometers to decimeters. Now again, we want to identify the prefixes here. I have hecto that comes before meters, and then I have deci that comes before meters here. So we're going from hecto to deci. So here's hecto, here's deci. So to do that movement on the prefix chart, I'm going to go 1, 2, 3 places to the right, and I basically just need to match that with the number. So 1.97, I need to put 1 zero behind that 7, and I'm going to go 1, 2, 3 places to the right. So let me erase this, and I would get the number 1,970. And of course, you're going to write your units that you're converting to, which in this case is decimeters. So 1,970 decimeters. Okay, let's take a look at another one. We have 0.38 kilograms to centigrams. So again, identify your prefixes. You have kilo here, and you have centi here. So here's kilo, and here's centi. So I'm going to go 1, 2, 3, 4, 5 places to the right on the prefix chart, and I just need to match that with the number part. So I have 0.38. I'm going to need to put 3 zeros behind the 8. 1, 2, 3. And now I'm just going to move the decimal point 5 places to the right. 1, 2, 3, 4, and finally 5. So let's erase this and put a comma in. So I'll have 38,000 and then write the units you're converting to. Centigrams. All right, let's take a look at one final problem. We have 93.98 decigrams to decagrams. So again, identify the prefixes here. You have deci, that comes before grams, and you have deca, that comes before grams. So here's deci, and here's deca. So on our prefix chart, we're going to go 1, 2 places to the left. So I'm going to take this number, 93.98. So I'm going to go 1, 2 places to the left. So that'll go right there. And I'll end up with 0.9398. And then write the units you're converting to, which in this case is going to be decagrams. So 0.9398 decagrams. Hello and welcome to Pre-Algebra Test Section 1 on converting between metric units. All right, so we want to perform each conversion, and we're going to start out with 12.35 hectograms to decigrams. So remember, when you work with the metric system, it's super easy to do conversions when you have a prefix chart like we have here. So when we start, all we basically need to do is identify our prefixes that are used in the conversion. So we're starting at hectograms, right? So hecto is the prefix, and then we're going to decigrams, so deci is the prefix there. So just identify those on the prefix chart. We have hecto here, and we have deci here. Now, all we need to do is take this number part for what we're converting, so 12.35, and we move our decimal point the same number of places and in the same direction as we move for the prefix chart, right? So we're just matching the movement. So if I'm starting at hectograms and I'm going to decigrams, I just think about, okay, I'm going from hecto to deci. That's 1, 2, 3 places to the right. I just match that with my decimal point. 1, 2, I need to put a 0 in, and then a third place to the right. So let's erase this, and we would have the number 12,350. And then, of course, I'm going to write the units that I want to end up with, which in this case is decigrams. So 12.35 hectograms is the same as 12,350 decigrams. All right, for the next one, I have 38.75 liters to decaliters. So if I look here, I don't have a prefix on liters. It's the basic unit, this right here. And then for decaliters, I have deca that comes in front of liters. That's going to be right here. Now on my prefix chart, to go from the basic unit to deca, I just simply go one place to the left. So I would match that movement with my number, 38.75. Just look at your decimal point, and again, just match the movement. So it's going to go one place to the left and end up right there. And if I erase this, I'd have 3.875. And of course, write what you're going to end up with in terms of units. That's going to be deca, and it'll be decaliters. So 38.75 liters is the same as 3.875 decaliters. Hello and welcome to Pre-Algebra Test Section 2 on converting between metric units. All right, so we just want to perform each conversion, and we're going to start out with 19.813 centigrams to milligrams. So essentially converting between metric units is very, very simple if you have a prefix chart available. So I have a prefix chart here. Basically what you want to do is look at the prefixes involved in your conversion. Just go ahead and highlight them and then highlight them on your prefix chart. So we have centi that comes before grams, and we have milli that comes before grams. So we're going from centi, which is here, to milli, which is here. Now take your number that's involved in the conversion, in this case it's 19.813, and just match the movement in terms of the number of places and the direction from your prefix chart with your decimal point in the number. So for example, here I'm going from centigrams to milligrams. So centi is your first prefix and you're going to milli. So that's one place to the right. All I need to do is look at my number, take the decimal point, and match that. So I'm going to go one place to the right here as well. And my new number would be 198.13. And then just follow it up with the units that you're converting to. So that's going to be milligrams. So 19.813 centigrams is the same as 198.13 milligrams. What about 475.32 decameters to decimeters? Well, again, identify the prefixes involved. You have deca here, that comes before meters. You have deci here, that comes before meters. And just locate those on the prefix chart. So you have deci here, you have deca here. Now we're going to take this number that's involved in the conversion. In this case, it's 475.32. And we're just going to match the movement as far as the number of places we move and the direction we move from the prefix chart with our decimal point in the number. So I'm going to go from deca to deci. So I'm going to take this and go 1, 2 places to the right, and I'll just match that here. I'm going to go 1, 2 places to the right. Go ahead and erase this, and I'll put a comma in. I'll have 47,532, and then follow that up with the units you're converting to, which in this case is decimeters. So 475.32 decameters is the same thing as 47,532 decimeters. Hello and welcome to Pre-Algebra Test Section 3 on converting between metric units. All right, so we just want to perform each conversion. And we're going to start out with 53.27 kilometers to meters. So converting between metric units is very, very simple, particularly when you're using a prefix chart. So the first thing you want to do when you're using a prefix chart is identify the prefixes involved in your conversion. So in this case, we're going from kilometers to meters. So I have kilo here, that comes before meters, and then I'm converting to the basic unit meters. Now locate those on the prefix chart. I have kilo here, and then I have the basic unit, which in this case is meters, right here. Now we just want to match the movement from the prefix chart in terms of how far we're moving, right? The number of spaces we move, and then in the direction that we move with our decimal point in the number part for what we're converting. So 53.27 is the number part, and I'm going from kilometers to meters. So on the prefix chart, I would go from kilo, and I go 1, 2, 3 places to end up at the basic unit, which represents meters in this scenario. And so we would match that movement here with our decimal point and go 1, 2, put a 0 here, 3 places to the right. And so we'd end up with the number 53,270, and then follow that up with the units that you're converting to. In this case, that's going to be meters. So 53.27 kilometers is equal to 53,270 meters. All right, for the next one, we're looking at 13 liters to milliliters. So again, we have the basic unit involved, which is right here. And then we have milli, which comes before liters. So milli is right here. So take our number part, which is 13. And then we're going from the basic unit, and we're going 1, 2, 3 places to the right to get to milli. So I'm going to match that movement here. So I'm going to put a decimal point here. I'm going to put 1, 2, 3 zeros behind it. And then I'm going to go 1, 2, 3 places to the right. And so this is going to end up being 13,000. So 13,000, and then again, just follow that up with the units that you're converting to, which in this case would be milliliters. So 13 liters is the same as 13,000 milliliters. Hello and welcome to Pre-Algebra Test Section 4 on converting between metric units. All right, so we want to perform each conversion. And we're going to begin with 0.4251 kilograms to grams. So the way we do this, we use a prefix chart. So here's the prefix chart here, and we just identify the prefixes involved in our conversion. So for kilograms, kilo comes before grams, and we'll locate that on the prefix chart right here. That's kilo. And then for grams, there's no prefix there because that's the basic unit. So we'll highlight that there. Now all we need to do is take this number part, which in this case is 0.4251, and match the movement that we do on the prefix chart with our decimal point in the number. So for example here, since I'm going from kilograms to grams, I'm going to go 1, 2, 3 places to the right. And so I would match that with this decimal point. I would go 1, 2, 3 places to the right. And so I'd end up with 425.1. And then write the units that you're converting to. In this case, that's grams. So 0.4251 kilograms is the same as 425.1 grams. All right, for the next one, we have 0.875 decaliters to centiliters. So again, we're going to identify the prefixes involved. So we have deca here, and we have centi here. Now, if I look at my prefix chart, here's deca, and here's centi. So I'm just going to match this movement with my decimal point in the number, so 0.875 here. And basically what I want to do, I want to go 1, 2, 3 places to the right to go from deca to centi. So I'm going to match that with my decimal point. I'm going to go 1, 2, 3 places to the right, and I'd end up with the number 875. Now, of course, then I want to write the units that I'm going to convert to. So then centi, and then liters. So 0.875 decaliters is the same as 875 centiliters. Hello and welcome to Pre-Algebra Test Section 5 on converting between metric units. All right, so we want to perform each conversion. And we're going to start out with 0.005318 kilometers to decimeters. Now, for metric conversion, the simplest way to do it is to use a prefix chart. Now, if you start out with a conversion, you look for the prefixes involved. So in this case, we have kilo and we have deci, right? It's what comes before meters. Just locate those on your prefix chart. So we have kilo here and we have deci here. So 0.005318. We're going from kilometers to decimeters. So from kilo, I'm going to start. I'm going to go 1, 2, 3, 4 places to the right. I just need to match that with my decimal point. 1, 2, 3, 4 places to the right. That's going to go right there. And I can erase all of this, and I can erase these zeros to the left of the 5. They no longer add any value to the number. So I'd have 53.18, and then follow that up with the units you're converting to, which in this case would be decimeters. So 0.005318 kilometers is equal to, or is the same as, 53.18 decimeters. All right, for the last one we're going to look at, we have 0.147 decaliters to kiloliters. So again, just look at the prefixes involved. We have deca and we have kilo. So if we look at those on the prefix chart, we have deca here and we have kilo here. Now I'm going from deca to kilo. So that represents a movement to the left. So I'm going to go 1, 2 places to the left. And I just match that with the decimal point in the number part. So 0.147. Let me kind of back that up a little bit. So again, 0.147. I'll need to put 2 zeros to the left of the decimal point. And then I'm going to go 1, 2 places to the left. And I'll erase all of this. So I'll end up with 0.00147. And then again, the units you're converting to. So kilo, liters. So 0.147 decaliters is the same as 0.00147 kiloliters.